In this comprehensive generative AI course, you'll dive deep into the world of generative AI, exploring key concepts such as large language models, data preprocessing, and advanced techniques like fine-tuning and RAG. Through hands-on projects with tools like Hugging Face, OpenAI, and LangChain, you'll build real-world applications, from text summarization to custom chatbots. By the end, you'll have mastered AI pipelines, vector databases, and deployment techniques using platforms like Google Cloud Vertex AI and AWS Bedrock. Bakhtir Ahmed Bapi created this course.
Generative AI is the most demandable skills nowadays across industries. If you see, all the industries have started using generative AI in their product development. If you want to level up your skill and if you want to crack good job nowadays with a good package, definitely you should know about generative AI. If you are looking for well-organized end-to-end complete generative AI course, I have a very much good news for you. Recently, I have published one amazing end-to-end generative AI course. So here I have covered everything you need to know to master the generative AI. This course will cover basics to advanced concept of generative AI. So here we are not only going to focus on the theoretical part, we'll be also focusing on the practical implementation of generative AI. We'll be exploring different kinds of large language model. With that, we'll be creating different kinds of generative AI based application. So let me show you the course content of this course. So guys, as you can see, this is the course content. As I already told you, we'll be starting from very basics of the generative AI and we'll be covering till advanced part of the generative AI. So here we'll be starting from introduction of the generative AI. So if you're completely new to this field, no need to worry. I'll cover each and everything you need to know about generative AI. Then we'll be learning about data preprocessing and embedding, because going forward, whenever we'll be using large language model, and to give your data to the large language model, first of all, you have to know how to process this data and how to generate the embeddings of the data. And to process our data, we need to know some of the techniques. So here we'll be covering these are the technique in this section. Then we'll be starting with the large language model. We'll be learning about different kinds of large language model. We'll be learning about commercial large language model. We'll be also learning about open source large language model. We'll be starting with the Hugging Face platform and its API, because if you see the Hugging Face is having all kinds of large language model. Whether it's a commercial model, whether it's an open source model, all kinds of model are available inside the Hugging Face platform. Then we'll be also learning about OpenAI and its platform, because if you see nowadays OpenAI is evolving a lot. They are coming up with different kinds of large language model, like they are coming up with image model, language model, okay, different kinds of model they are bringing. So in this course, we'll be learning about the complete OpenAI and its platform, so that you can use OpenAI platform to implement any kinds of generative AI based application. We'll be learning about prompt engineering, because if you see, prompt is everything for the large language model. So if you are designing a good prompt, definitely you will be getting a good response from the large language model. So here we'll be learning how we can design an efficient prompt, and we'll be also learning about different kinds of prompting inside large language model. In this course, we'll be mastering the vector database. We'll be learning different kinds of vector database like Pinecone, Weaviate, ChromaDB, Fies, and so on. This vector database will help you to create a knowledge base. So whenever you will be creating any kinds of RAG based application, any kinds of LLM powered application, this vector database concept will help you a lot. In this course, we'll be mastering different kinds of generative AI based framework, like we'll be mastering LangChain, LlamaIndex, Chainlit, and so on. These are the framework will help you to implement different kinds of Gen AI based application. In this course, we'll also learn one very important topic inside generative AI called retrieval augmented generation, that means RAG. So we'll be learning how we can create different kinds of RAG based application with our custom data. Even we'll be also learning how we can fine tune any kinds of large language model on top of our custom data. After completing all the topics inside generative AI, we'll be starting with some end-to-end project implementation with the deployment. So here we'll be implementing this kinds of project from scratch. We'll be using modular coding to implement this kinds of project. At the last of the course, we'll be also discussing about LLM ops. If you see, inside generative AI, LLM ops is the most trending topic nowadays. We'll be learning how we can use different kinds of LLM ops platform, like we'll be learning about Bedrock, Vertex AI, and we'll be learning how we can use these at the platform to implement efficient large language based application. So yes, this is the complete curriculum of our course. So if you want to start your career with generative AI, guys, so this would be the amazing course for you. So make sure you complete this course till the end. And this is my promise, guys, you will become champion inside generative AI. With that, guys, all the best, and I will see you in the course. Hi everyone, welcome to the course of Generative AI. My name is Bakhtir Ahmed Bapi and I am a data scientist and mentor. I am having more than 4 years of working experience in the field of machine learning, deep learning, generative AI, ML ops, and so on. I have already worked with so many multinational companies as a developer. Even I also work with so many edtech company as a mentor. I have also taken lots of batch related generative AI, machine learning, deep learning, computer vision, natural language processing, and so on. So throughout the entire course, I'm going to be your mentor. So as I already have some experience from the industry, so in this particular course, I'm going to share my knowledge and experience with you. So in this course, we'll be starting with the very basics concept of generative AI and we'll be completing till advanced part of the generative AI. So if you're a beginner, if you want to start your career with the generative AI, so this course is for you. I have designed this particular course in such a way so that anyone is coming from any kinds of domain, they will be also able to understand. So if you're from non-tech background, if you're from tech background, it doesn't matter. So if you're interested in generative AI, only you just need to start with this course. Everything I will take care. Apart from the theoretical understanding, I'm also going to show you lots of practical in this particular course. We'll be doing lots of hands-on in this particular course. We'll be solving different problem statement in this course so that your understanding would be more clear. Hello everyone, welcome back with another video. In this video, we'll be discussing about what is generative AI. So before discussing about generative AI, first of all, let me introduce some of the real world application of the generative AI you are using in your day-to-day life. So I think you know about ChatGPT, Google Gemini, Meta Llama, right? So these are the application you are using in your day-to-day life. I hope everyone has used ChatGPT at least, right? So inside ChatGPT, what we can perform, we can give any kinds of prompt. We can do the conversation, we can do the summarization, we can generate the content, we can generate the code, we can do the text summarization, any kinds of task we can perform in the ChatGPT, right? So similar wise, Google has developed their own product called Gemini. Okay, Google Gemini. So with the help of Google Gemini also we can perform the same things. The things actually we perform usually in our ChatGPT. So the same thing we can perform with the help of Meta Llama 2 as well. That means ChatGPT is developed by OpenAI, Google Gemini is developed by Google, and Llama is developed by Meta. Okay, Meta AI, that means Facebook. So all the tech giants companies are working on generative AI. Day by day, they are improving this particular generative AI. They are bringing actually different large language model, and they are launching different application. Okay, for the users. Nowadays, all the companies are using generative AI to implement their product. So currently in the market, generative AI having more popularity. So that's why you have to know what is generative AI exactly, how generative AI works. And definitely if you want to work in the current job market, you have to know about this generative AI. You have to learn about this generative AI. Okay, this is the idea. See, all the application I showed you here like ChatGPT, Google Gemini, Meta Llama. So they are using something called large language model in the backend. Okay, with the help of large language model, they are able to perform these are the operation. Now, first of all, let's try to understand what is generative AI exactly. See, generative AI is nothing but generative AI generates new data based on training samples. Generative model can generate image, text, audio, video, and so on data as an output. So I think you have already worked with machine learning, deep learning, computer vision, and so on, right? So there you used to use something called discriminative model. And what is discriminative model? Based on some input, actually, it will predict the output of that particular data. Okay, so this was actually discriminative model. And to train the discriminative model, actually, we used to use something called label data. That means whenever we used to prepare the data for the training, we used to prepare the, let's say, input data as well as the output data. That means you have to pass the X data and Y data. That means input and output both. Okay. And if you give input and output both, it will learn the relationship between input and output. It will learn the pattern from the data. Then it will able to predict something on top of the test data. So that was the idea in the discriminative model. That means in the prediction model, right? But generative models are different. Okay. So generative models can generate a new data based on the training samples. So here you will be giving some training sample, which is called unstructured data. So based on this training sample data, it will try to generate some new data. That means inside Gen AI, whenever you are giving any kinds of unstructured data as an input, your generative model will try to understand this unstructured data. It will learn the pattern from the unstructured data, and it will try to generate something from that particular sample you are giving. Okay, this is the idea. And output can be anything. It can be text, it can be audios, it can be videos, and so on. Okay, as I already told you, inside generative AI, we not only work with the text, but also we also work with the image, videos, audios, and so on. Okay, so all the unstructured data can be used inside generative AI. This is the idea. So that's why I've written generative AI is a very huge topic. Inside generative AI, actually, we are having generative image model as well as the generative language model. That means you can work with the languages, that means text. You can also work with the images, videos, okay, and audios. So there is another model you can consider, generative audio model. But at the end, you are converting this audio to the text representation, that means language representation. That's why I haven't mentioned this audio model separately. Okay, this is the idea, because audio is nothing but it's a frequency, and from the frequency we can convert to the textual representation. Okay, this is the idea. There are so many API you will get. Even Google has the API. You can let's say convert speech to text. Okay, with the help of speech to text, you can easily convert any kinds of audio to textual representation. Okay, this is the idea. That means what is generative AI? Generative AI is nothing but it generates new data based on the training sample you are giving. And generative model can generate any kinds of output, whether it can be image, it can be text, or it can be audios. Okay, now let me tell you how they got the idea, like how the generative model can work. See, this idea had taken from real life only. Let's say if I give you 10 different cat book. Okay, let's say if I give you 10 different cats book, and if I tell you just try to read all the 10 different cat book. Let's say you have read all the 10 different cat books. Now if I'm asking anything related cats, okay, you will be able to give me the answer because you have already studied about the cats. Like 10 different books I have given, and this was the enough data for you, right, to learn about the cats. So that's why if I'm asking anything related to the cats, you will be able to give me the response. So here you have become one cat model. Okay, you have become one cat model, and that is why if I'm giving any kinds of question, you will be able to give me the response. Okay, so similar concept applied in the generative AI also. So they implemented one model called generative model. In the generative model, they feed actually tons of data. That means huge amount of data they trained, okay, that particular model. And then actually they were giving some kinds of question, and that particular model was able to give the response. Okay, this is the idea. That means here you are feeding tons of unstructured data, and your model is able to, let's say, learn the pattern from the unstructured data. And there would be a position your model will be able to capable enough to give any kinds of response, okay, based on the question you are asking. Now you can ask me why generative models are required. See, I can give you thousands reasons of the generative model requirement, but here I have listed down some of them. So the first thing you can consider, understand the complex pattern from the data, because nowadays you can see people are using unstructured data a lot. Unstructured data means it can be text data, it can be audio data, it can be videos data, right? So this is called actually unstructured data. And in today's world, actually people are using internet broadly, and in internet actually people are generating huge amount of unstructured data. Okay, they are using different social media, they are using different platform. So that's how actually they're generating tons of unstructured data. So that's why it's very hard to understand the pattern from these kinds of unstructured data without traditional machine learning model. Okay, so that's why this generative model comes into picture. So it can easily understand the complex pattern from these kinds of unstructured data. The second thing you can consider the content generation. That means your generative model can generate any kinds of content. It can generate code, it can generate, let's say, any kinds of story, it can generate any kinds of music, any kinds of videos. Now I think nowadays you have seen like there are so many applications came in the market. So if you give any kinds of prompt, it will generate the video for you, okay, the complete video for you. That means it is generating some content. Okay, it is generating some content based on the prompt you are giving. And that's how for the content creator also it is becoming one of the very used tool, okay, for their content generation and all. Let's say you are a blog writer. Now you don't need to write the blog from scratch. So what you can do, you can just pass the topic and your model will generate the blog for you. And what you can do, you can just modify this particular blog with respect to your requirement and you can publish, okay, anywhere. You can also generate any kinds of videos. You can also generate any kinds of reels, okay. Everything is possible nowadays with the help of these generative models. Okay, so that is why content generation is one of the very important, let's say, features inside generative models. Okay, I can talk about. Now the third thing you can consider, build powerful application. As I already told you, we are already using tons of powerful application in our day-to-day life, like ChatGPT, Gemini, okay, then Llama. So different actually powerful application we are using in our day-to-day life. And just try to think about when we didn't have these kinds of application, we had to complete lots of work actually manually, but nowadays we are having this kinds of powerful application. Now you can do any kinds of work actually in a few seconds. Okay, it is possible. Let's say if I give you one example, as a developer, whenever let's say you are getting any kinds of error, okay, from your, let's say, application, what you can do, you can copy that error and you can ask to the ChatGPT. ChatGPT will give you the solution, okay, how you can solve it. But previously when we didn't have any kind of ChatGPT, what we used to do, we used to search that particular error inside Google. We used to open the Stack Overflow and we used to see lots of, let's say, solution. Then we used to solve that particular, let's say, error. And nowadays, actually, we are using this kinds of application and it is actually saving lots of our time. So we don't have to spend actually lots of time to fix any kinds of bugs. In a few seconds, actually, it is possible nowadays if we are using this kinds of powerful generative AI based application. Okay, this is the idea. Those who have already studied about artificial intelligence, machine learning, deep learning, maybe you have already seen this kinds of Venn diagram. Okay, this is the Venn diagram of our AI, the complete AI. Now you can see machine learning is a subset of artificial intelligence. Deep learning is the subset of machine learning. And now here you can see generative AI is the subset of deep learning. Okay, it is the subset of deep learning. That means machine learning is the subset of artificial intelligence. Deep learning is the subset of machine learning, and generative AI is the subset of deep learning. Okay, this is the complete Venn diagram of the complete artificial intelligence. Okay, I hope it is clear. Now let's try to see the difference between discriminative model and generative model. You can see discriminative model is nothing but it's just a prediction model. Let's say here you have given two input. One is the cat image, another is the dog image. What your discriminative model will do, it will try to predict whether it's a cat image or whether it's a dog image. That means you are trying to do some prediction here. I think you already use this kinds of model in your deep learning. Let's say whenever you used to perform something called image classification, there we had different model like ResNet 50, Inception V3, right? MobileNet, VG16. So with the help of this particular model, we can perform the image classification task. On the other hand, generative model can take actually any kinds of sample data, any kinds of noise data, and from that particular noise data, it will generate a complete new image for you. Okay, new data for you. Now let's say here you are passing one noise data. Noise data means it can be any kinds of unstructured data. And what generative model will do, it will try to understand the pattern. Okay, it will try to understand the pattern from these kinds of data. Okay, then it will generate a new data for you, new data point for you. This is the idea. Okay, this is the idea of the generative model. See, I have kept another example here. Let's say, so here we are using discriminative model to classify the music type. You can see here we are giving actually different music, rock, classical, and romantic. So here your discriminative model, that means your discriminator deep learning model will try to classify whether it's a rock music, whether it's a classical music, or whether it's a romantic music. On the other hand, generative model, what it will do, you will just give some music sample. Okay, and generative model will try to understand the pattern and it will generate a complete new music for you. Maybe you have already heard of AI has created music, AI has created songs, AI has written story. How? That's how actually they're using something called generative model. They're actually feeding lots of training samples. Okay, and this model is learning and it is generating a new content. Okay, with respect to the data they are giving. This is the idea of the generative model and the discriminative model. I hope now it is clear. Now, if I discuss a little bit low level, like how things are working here. See, maybe you have heard of something called supervised learning. Okay, in supervised learning, what we do, we give the X data as well as the Y data. That means input and output. And here we try to find the relationship between our input and output. Okay, this is called actually supervised learning. And whatever actually, let's say, discrete model actually we're using, it is called actually supervised learning. On the other hand, we are having another learning called unsupervised learning. In the unsupervised learning, what we used to perform, we used to perform something called clustering technique. Let's say here we are only giving the X data, that means the input data. And what my model will try to do, it will try to make a cluster. Let's say this is one cluster, this is another cluster, this is another cluster. That's how it is separated out my data. Okay, that's how it will find out the relationship between the data. Okay, this is the idea. Now you can consider this unsupervised learning as a generative model. So generative model will also work in the same way. So instead of actually finding the relationship, what it will try to do, it will try to make a cluster. Okay, it will try to make a cluster from the unstructured data actually will be feeding. This is the actually low level actually understanding I'm giving you how things are working here. But on top of that, they have added some more technique to actually build this kinds of generative AI model. Okay, this is the idea. So in summary, actually you can see generative AI is a subset of deep learning, and generative models are trained on huge amount of data, as I already told you. While training the generative model, we don't need to provide any kinds of label data. We only give the unstructured input data, because whenever you are working with huge amount of data, it's not possible to label the data. Okay, that's why you are giving the unstructured data as an input to the generative model. So here you can see in generative AI, we give the unstructured data to the large language model for the training purpose. And whatever things I explained so far, you can see what your discriminative model will do. It will try to actually predict whether it's a dog image or whether it's a cat image. Okay, by finding the relationship. On the other hand, your generative model will try to make a cluster. Okay, let's say this is a cat cluster, this is a dog cluster. Okay, then with the help of that, it will able to generate a new content from you. I think you have heard of something called GAN, the generative adversarial neural network. Okay, so GAN is also called generative model. Okay, because here you will be giving noise data, and from the noise data itself, it will able to generate a new content. Okay, new data. This is the idea of the GANs. So far I told you about generative model, but what exactly this generative model? See, generative model is nothing but it's a large language model, which is also called LLM. See, a large language model is nothing but it's a foundational machine learning model that uses a deep learning algorithm to process and understand the natural language. These models are trained on massive amount of text data to learn patterns and entity relationships in a language. It can be also considered in a image data as well. Okay, not only text data, you can also use LLM for the image as well, because I told you we are having two kinds of model, generative language model, generative image model. Okay, so you can also use image data here, not only text data. And it is a language model which is responsible for performing tasks such as text to text generation, text to image generation, image to text generation. As I already told you, generative model can support actually all kinds of data. You can generate text to text, you can generate text to image, even you can also generate image to text. Okay, everything is possible with the help of this large language model nowadays. Okay, and we also call it as multi-model. That means you can perform multiple tasks here, not one specific task. You can perform multiple tasks like text to text, text to image, and image to text generation. Apart from that, you can perform some more tasks. Let's say you can perform language translation, you can perform text generation, you can perform, let's say, text classification, you can perform sentiment analysis, name entity recognition, all kinds of tasks you can perform with the help of only one model, and which is nothing but our large language model. Okay, and large language model is nothing but our generative model. Okay, this is the complete idea about our generative AI. I hope it is clear now. Now let's try to understand what makes LLM so powerful. As I already told you, in case of LLM, one model can be used for whole variety of the task. Okay, I told you na, text generation you can perform, chatbot you can perform, summarization you can perform, translation you can perform, code generation you can perform. That means whatever task actually you have inside the NLP, all the tasks you can perform with the help of one model, which is nothing but large language model. So that's why we call this LLM is so powerful, and that makes LLM so powerful, because in our traditional model, whatever model we used to use, that means the language model only, we can only perform one specific task. Let's say you want to do actually language translation. For language translation, you need to only train one language translation model. That model can't do the code generation, or let's say text summarization. That model can't perform. But if you're using large language model, you can perform all kinds of tasks with the help of one model only. Okay, so that's why LLM is so powerful, because of this particular idea. So as I already told you, if you're using your traditional actually language model, it can only perform one specific task at a time. Let's say you want to build a sentiment analysis. So one model you have to train for the sentiment analysis, which will only able to do the sentiment analysis, whether this particular, let's say, sentiment is positive, neutral, or negative. Let's say you want to perform language translation. You have to train another model for the language translation, and that model will be able to translate any kinds of text. Okay, that means you have created two separate model, okay, for two separate tasks. But if you are using large language model, you need to only train one specific model, okay, and that can perform multiple tasks. This is the idea of large language model. So let's see some of the large language models. So here you can see we are having Gemini, GPT, XLM, then we are having T5, Llama, Mistral, Falcon. Apart from that, there are so many large language models are available over the internet. I'm going to discuss, I'm going to show you each and everything. So here I just mentioned some of the large language models just to show you. But I will tell you how you can see all the large language models are available over the internet. Even I will also show you how you can access those models and how you can use those models to create your application. Okay, on top of it, everything I'll try to clarify. So yes, guys, this is the introduction of generative AI. Now I think you got the clear-cut idea about generative AI, like what exactly is generative AI, and inside generative AI actually what are the things are available, and why it is actually mostly used technology inside any kinds of software product nowadays. And inside generative models actually what is uses, it is uses something called large language model. And not to worry, I'll discuss about large language model in detail, like how large language model works, and inside that what are the architecture they're using. Everything I will try to clarify. And now you can ask me what is end-to-end pipeline of generative AI. No need to worry, I will explain each and everything, what is pipeline and all, and why pipeline is super important whenever you are working in the generative AI field. See, it's not like that whenever you are getting some problem statement from your company, whenever let's say you are receiving the data, it's not like that you will be directly applying the model on top of it. Before applying the model, we have to perform some specific task, okay? And those step-by-step task is called pipeline. So you can see generative AI pipeline is a set of steps followed to build an end-to-end Gen AI software. Okay, that means here you will be breaking the problem statement into several sub-problems. Then you will be trying to develop a step-by-step procedure to solve them. And here you can see, since language processing is involved, okay, inside generative AI, so we would also list all the forms of text processing needed at each step. This step-by-step processing of the text is known as a pipeline. Okay, that means that means whenever you are getting any kinds of problem statement from the company, first of all, break that problem statement in a several sub problems. Okay, then try to solve one by one. And to solve that, you have to perform some steps. Okay, you have to perform some steps, and those steps is called actually pipelines. Okay, pipelines inside generative AI. Now let's see one end-to-end pipelines actually we have to follow for all the projects we'll be developing in futures. See, in generative AI pipeline, we are having, these are the steps we have to follow. The first step actually we have to follow the data acquisition, because here data is everything, right? At the end, you have to work with the data here. So first of all, you have to get the data, and these steps falls into data acquisition part. Okay, then after that data acquisition, we have to perform something called data preparation. Okay, what is data preparation? I will let you know. That means here you will be doing the cleaning of your data. Okay, after that, you will be starting with something called feature engineering. Inside feature engineering, there are so many steps you can follow. Like, so the main step actually you'll be doing inside feature engineering called text representation. That means you will represent your text to the vector, that means number, so that your model can take the input. Then after that, you'll be doing the modeling. Then you have to select different model and you have to feed the data there. Okay, this is the idea. After modeling, what you have to do, you have to evaluate that particular model, because unless and until you are not evaluating the model on top of test data, you won't be able to decide whether this particular model is suitable for our production or not. Okay, then once, let's say you got your let's say production model, what you can do, you can do the deployment of your model. You can host your model so that other people can use your model. Okay, other user can use your model and they can give the feedback. Okay, based on the feedback, last step what you can do, you can perform monitoring and model updating. That means you have to monitor, you have to keep on monitoring your application. Like I think you saw the ChatGPT, right? So previously I think you saw in ChatGPT, whenever let's say you are giving any kinds of prompt, so it will give you one actually, let's say input form. It will tell you, are you enjoying this ChatGPT, or any kinds of feedback you want to give or not. So there actually they were taking the input in real time. Okay, this is called actually monitoring. Okay, monitoring their application. That means they're monitoring whether this application is working fine or not in the production. If something going wrong in the application, if let's say user is giving negative feedback, that time what they will do, they will try to update this model again. Okay, this is the idea. So it's not like that you are only building your model, you are only deploying your model. It's not like that. You have to monitor the model in production, and based on the feedback, you have to keep on updating the model itself. Okay, this is the complete idea. And these are the steps involved inside the generative AI pipeline. I hope it is clear. Now let's break down all the, let's say, pipeline steps one by one and try to understand what we have to do in each and every step. The first step was actually data acquisition. So inside data acquisition, you can follow some step to collect your data. So the first thing, you have to check whether you have available data or not. So available data. Available data means, let's say you are having a CSV file directly, you are having, let's say, text file, you are having, let's say, PDF documents, you are having docs documents. Then you might also have something called Excel SX. Okay. So if you have, these are the files. Apart from, if you have any other file format, it's completely fine. But first of all, you have to check whether you have available data or not. Okay, this is the idea. Now, if you don't have the available data, what you have to do, you have to look for other data. Okay, other data. Other data means you can collect the data from the database. You can see in the internet whether someone is having the data set or not. Then you can also use the API. Let's say someone will give you the data, but you have to fetch the data through the API. That time actually what you can do, you can collect the data from the API itself. Okay. Then you can perform something called scraping. That means web scraping. Let's say you don't have the data in database, internet, API. Then what you can do, you can do the web scraping. Okay, web scraping means you will be scrapping the data from a website. Okay, this is the idea. Now there is another possibility, you have no data. That time what you will do? Okay, that time what you will do? That time you have to create your own data. Create your own data means either you can collect the data. Okay, either you can do the survey, you can collect the data, or what you can do, you can use large language model to generate the data. Okay, LLM to generate data. Nowadays, actually, you will see people are using OpenAI. Okay, OpenAI GPT model. Okay, GPT model to generate the data. Okay, so with the help of LLM also, you can generate your own data. But whenever you are creating your own data, there is a possibility, let's say your data will be less. Let's say here I will just write, you have to note Let's say whenever you are collecting your own data, your data quantity might be less. So that time what you can do, so let me write here, if you have less data, then you can perform data augmentation. I think you know what is data augmentation. Okay, so data augmentation is nothing but you will be augmenting the data. Let's say I'll give you one example. So the first augmentation technique you can perform, so let me give you the example. You can do something called replace. You can do replace with synonyms. Okay, now how to do the synonyms? See, let's say here is one example I will give you. Let's say I am a data scientist. Okay, so let's say this is my text. Now what you can do, you can just replace this synonyms. So here you can write I am a AI engineer. That means you are replacing this particular entity with this entity. So this is called actually replace with synonyms. Okay, this is the idea. I hope you got it. Because here you will be working with textual data mostly. And if you have the image, that time what you can perform. So there are lots of image augmentation technique as well. Let me show you. So you can simply search image augmentation. So there are different technique you can follow. See, let me show you one example. Let's say this is the example I can show you. Let's say this is your original image. So what you can do, you can do the horizontal flip, you can do the vertical flip, you can do the rotation of the image, you can also do the negative rotation, you can do the blur operation, you can change the brightness, you can add some noise, you can add some darker. Okay, so that's how actually you can change the original image. Okay, you can change the original image and make different variants. Okay, this is called actually image data augmentation. Because I already told you, inside Gen AI we use both kinds of data, whether it can be textual data, it can be image data, it can be audio data. Okay, anything actually you can consider here. Now the next technique you can apply, which is called bigram flip. Bigram flip. Now you can ask me, sir, how to perform bigram flip? See, it's very easy. Let's say I'll give another example. I am Bappy. All right. Now you can write this sentence like that. Bappy is my name. Okay, so this is called actually bigram flip. That's how actually you can also do that data augmentation, because at the end you are increasing the data. That is the idea. And whenever you are increasing the data, it should have the meaning. It doesn't have the meaning, that means there is no use of the data. So you have to make sure whenever you are performing, these are the technique, this data should have some meaning. I hope you are getting my point. Now the next thing you can perform, third step you can perform, back translate. Back translate. Now how to perform back translate? Let me show you. So let me go to my translator. So I'll open the translator. Okay, Google Translator. Let's say here if I write one sentence, or I can just copy one story. Let's say here what I will do. Let's say I will copy this text, and here let me paste it. Now you can see it is translating to the Bengali. Now what I will do, I'll copy this Bengali translation, and here the input language I'll be selecting the Bengali right now. So let me select the Bengali, and I can paste it here. Now here you can select any other language. Let's say I'll select Spanish. Now see, Spanish text it is giving. Now let me copy. Okay. Now what I can do again, I can come here, I can paste the Spanish text, and let's say I want to convert to English again. So here let me select the English. You got your English text. Now so here if you see carefully, some of the word would be different, okay, than your previous actually text you have copied after doing the bigram flip. That means you will be converting a language to another language, that language to another language, then again in your English language. So that's how if you do multiple time translation, you will see some word would be changed. And see, this will work if you have actually lots of text, actually lots of sentence, not like that you are only copied 1 to 2 line. If you have multiple, let's say line, multiple text, that time actually the reflection actually will able to see. Okay, I'm just only showing you how we can perform the back translation, because there are so many API nowadays inside Python you can use for the back translate. I think translation API is already there. With the help of that, you can do the translation. First of all, let's say you have the English text. First of all, try to translate to the Hindi to, let's say, Spanish to English again. That's how you can do the back translation and you can increase the data. So this is another amazing data augmentation technique you can follow. Okay, I hope you cleared. The last step actually you can follow something called add additional data or additional noise. How we can add additional noise? Let's say here you have one sentence, I am a data scientist. So with this sentence you can add one more line. Let's say I love this job. Okay, so this is your additional data or additional noise you have added, okay, with your data. So again, this is called actually data augmentation technique, and again it's an amazing technique you can follow, okay, altogether. So these are the steps actually you can perform inside data acquisition. Okay, so first of all, try to check whether you have available data or not. If you don't have, try to see the other data. If you don't have, try to create your own data. For this you can use large language model. Even I will also show you how we can generate your data with the help of large language model. And after generating, let's say if you have less amount of data, in that case you can perform something called data augmentation technique. Inside data augmentation technique, these are the steps you can perform. Okay, so this is the first step of the pipeline. Now let's discuss the second step of the pipeline. Okay, the second step, I think you remember, data preprocessing. So inside data preprocessing you can perform cleanup operation. Okay, cleanup operation, that means you can remove HTML tags, then you can remove, let's say, emoji. You can do the spelling check, okay, spelling correction, fine. So these are the technique actually you can perform inside cleanup. Now there is another step you can follow called basic preprocessing. I'll tell you what are the basic preprocessing are available. Even I will also show you the practical how you can perform. Then you can also perform something called advanced preprocessing, because nowadays the application actually we have, let's say, ChatGPT, Gemini. So these are the actually advanced application, advanced, let's say, large language model. So for this we have to also perform some advanced preprocessing technique. Okay, let's say whenever I'm having that data nowadays, because let me show you. Let's say if I open my ChatGPT, okay, if I open the ChatGPT, see if I give any kinds of emoji nowadays inside ChatGPT, still it will be able to understand. Let's say if I give this haha, okay, haha, let's say emoji. Now if I send it to my ChatGPT, see, it is automatically detecting what's so funny. Okay, so that's kinds of text also we need to handle, because whenever we are collecting the text data, it will have emojis, it will have HTML tags, okay, so many things it will have. So sometimes it is also necessary to keep the emojis, because I told you now, this kinds of application is advanced, so it is also understand the emojis, any kinds of text. So we also need to handle these are the, let's say, text in that time. Now inside basic preprocessing, let me just write here, inside basic preprocessing. So inside basic preprocessing, the very important things you have to perform something called tokenization. Okay, so you have two kinds of tokenization. One is called sentence level tokenization. Another one is word level tokenization. So I'll be discussing each and everything, no need to worry. And there are some optional preprocessing are available. So inside optional preprocessing, the first thing you can perform, stop word removal. Okay, stop word removal. Then the second things you can perform something called steaming, and this is like very less used nowadays. Okay, less used actually technique. The third thing you can perform something called lemmatization, and the lemmatization actually more used. Okay, I'll tell you what is steaming, lemmatization whenever I'll show the practical, that time I'll discuss. Then the fourth things you can perform something called punctuation removal. So punctuation means, let's say you have question symbol, you have dot, you have comma, you have exclamation sign, okay, you have dollar symbol. So these are the things are actually punctuation. So you have to also handle the punctuation. Then you have to perform something called lowercase. Then the sixth, you can perform something called language detection. Because nowadays, if you open the ChatGPT or Gemini, if you give any kinds of language, it will first of all detect in which language you are asking the question. Based on that, it will give you the reply, okay, in the same language. So they are also applying this language detection technique, okay, in the backend. So that's actually one real world product implement. Okay, it's not like that you are getting the data, you are directly applying the model. It's not like that. So you have to follow the entire pipeline to build the end-to-end software. Okay, that's why I'm showing you these are the pipeline. Why this generative AI pipeline is super important, and what are the steps are involved, okay, inside the pipeline, so that after learning it, it would be easy for you to develop any kinds of software in future. And this is my promise. If you understand this, okay, if you can do this, you can design any kinds of software in future. Okay, because what is generative AI? Generative AI is nothing but just a technology. So you have to use the technology. You have to learn how to use the large language model, how to prepare the data for the large language model. Okay, how to use, let's say, a LangChain, how to use vector database. You have to connect everything together. Then you have to build one application. That is the idea only. But the root things available inside the pipeline, how you're designing the pipeline, whether pipeline has all the steps available or not. I hope you're getting my point, right? So now I think these are the steps are clear. But I think some of them still you are getting confused, like what is steaming, what is, let's say, lemmatization, what is, let's say, why we have to perform the lowercase operation, and what is this tokenization. See, let me just discuss all of them one by one. So first of all, let me discuss the tokenization. That means, let's say you are having a sentence here. Let's say my name is Bappi. So this is a sentence, right? This is a complete sentence, right? So whenever I will be converting this sentence to number, that means vector representation, first of all, I have to actually do the tokenization. Tokenization means you will be taking the individual words, let's say like that, my, comma, name, okay, comma, is, comma, Bappi. This is called actually word level tokenization. Okay, word level tokenization. Okay, that means you had one complete sentence, you just did the tokenization and you got the word as a token, okay, everywhere. Now you can take the word and you can convert to number. There are some technique we can follow. I'll tell you those are the technique, what are the technique you can follow to convert your text to number representation. Okay, and there is another technique called let's say sentence level tokenization. Let's say you are having a sentence like that. Let's say my name is Bappi. I am a data scientist. Okay, now if I perform sentence level tokenization, so sentence wise actually I have to convert. So it will come like that. My name is Bappi. So this is my one token, then comma, then I am a data scientist. Okay, this is another token. That means two token I'm having in the list. Okay, this is called actually sentence level tokenization. Sentence level tokenization. Okay, so we'll be using this word level tokenization a lot. Sentence level you can also use. Sometimes you have to use sentence level tokenization. Sometimes you'll be using word level tokenization. But most of the application I saw, people are using word level tokenization. That is the idea. So this is what actually our tokenization. Okay, now let's try to understand what is steaming. See, steaming is nothing but you are bringing one word in a root form. Let's say here we are having three kinds of word: play, played, and playing. So if you see them carefully, meaning are same, yes or no? Meaning are same, only the word representation is different. Now instead of taking actually three, okay, separately, what I can do, I can convert in a root form. So root form is nothing but play. Okay, because play represents sports. Okay, sports. So this is called actually steaming. That means you have different actually word form, that means different verb form, and you are trying to bring in a root representation. Okay, this is called actually steaming. And again, it's important because it will reduce the dimension. Okay, it will reduce the dimension whenever, let's say, you will be converting your data to the vector representation. Because if you have three word, so it will create actually three dimensions separately. But if you convert it to one, let's say word only, so it will only have one dimensional. And we know that inside artificial intelligence, dimension is like the issue. So if you have, let's say, more dimension, that time your model will get confused, because there is a concept of curse of dimensionality. So you have to also take care about the dimension. Okay, that's why we perform this steaming operation. And lemmatization is the same. Okay, the way actually perform the steaming, lemmatization is also same. Only whenever you will perform the lemmatization, your root meaning of the word would be readable. But whenever you will perform actually, let's say, steaming, sometimes it won't be readable. I'll tell you whenever I'll do the practical of it, that time actually we'll get it. Okay, what I'm trying to say. That is the idea. Now you can ask me what is lower casing, okay? Because punctuation you already know. Now you can ask me why lower casing is important. Why you have to perform the lowercase operation. Let's say if I write two sentence, Buppy is very good boy and Buppy is a data scientist. Let's say this kinds of sentence we are having. Now here you can see, I think Buppy and Buppy, both name are same, but here you can see the first character it's a capital one, the second character it's a lower one. So as a human, actually you can consider these two Buppy are same, but whenever you will be passing to the model, that means in your computer will be considering these two word is a different word, because here you are using capital and here you are using lowercase character, because all the character is having their ASCII value, right? That means the ASCII code, Unicode. So with the help of that, it will consider these two words are separate. So that time, this Buppy would be different, this Buppy would be different, although they are same. Okay, this is another issue. So that's why we perform lowercase operation. So whenever actually we are having the uppercase, we'll try to convert to the lowercase. Okay, we'll try to convert. So let me show you. We'll try to convert to the lowercase. Okay, so this is now you can see this Buppy and this Buppy will become same. Okay, now if you give pass to the computer also, your computer will identify this Buppy and this Buppy is the same right now. Okay, so that's why we perform the lowercase operation, so that my model won't be getting the confused. Okay, this is the idea. So I think most of the things I clarified, and yeah, so everything I'll show you as a practical as well, how we can perform as a practical. I'll discuss it. Okay, no need to worry. Now apart from basic pre-processing, I also told you we have something called advanced pre-processing as well. Now let's try to see what are the steps are involved inside advanced pre-processing. So inside advanced pre-processing, we have something called parts of speech tagging. Parts of speech tagging. So if you're good with English grammar, I think you know what is parts of speech. Okay. Then you are also having something called parsing. Then you have something called co-reference. Okay, co-reference resolution. Now, if you want to understand them, let me show you one image. I think then this part would be clear. So guys, I think you can see this image. So here you can see this is the input text we are having. Chaplin wrote, directed and composed the music of for the most of his film. Now, if I perform tokenization and lemmatization, so I already told you what is tokenization. You will be taking individual words. See, here I have taken individual word here. And if you perform the lemmatization means it will bring the let's say any kinds of verb in a root word. Now you can see wrote. If I bring to the root word, it will be write. Directed, it would be direct. Okay. Then compose, it would be composed, it would be compose. So that's how actually you can understand the tokenization and lemmatization. Now, what is POS tagging? POS tagging means parts of speech tagging. The things I showed you in my advanced pre-processing. So this is what actually parts of speech tagging. That means you are assigning what is noun, what is verb, what is adjective. Okay. So that's how you are defining different kinds of parts of speech. If you're good with grammar, I think you will be understanding better than me. Just try to consider here you are tagging everything. That means you are tagging all the, let's say, noun, verb. Okay. Then pronoun, everything you are tagging. Now there is another one called parsing. Okay. I think I showed you parsing. So this is the parsing tree. That means you will be creating a tree. And inside this tree, you will have the entire sentence word. You can see Chaplin wrote, directed. Okay. All the words. So in the parts tree, you will be again assigning the POS tagging. Apart from that, you will be also dividing. These are the word in a separate form. Again, this is a advanced actually grammatical rules you have to learn, but no need to worry. Let's say whenever you will be working in the industry, there you will have something called domain expertise. Okay, let's say language expertise actually people you will get, so they will help you to do it. Because I know as a developer, you don't know about, let's say, this English grammar and all. But whenever you will be designing the software, that time language expert will help you. Okay, how we can perform the parsing, how we can perform the POS tagging, everything they will help you out. Now, this is the last example, co-reference resolution. So co-reference resolution means, let's say, Chaplin wrote, directed and composed the music for the most of his film. Now here Chaplin and his, it is indicating the both person, it is indicating the same person, right? So this is called actually co-reference resolution. Sometimes your model has to understand this Chaplin and his. So it is mentioning the both, it is mentioning the same person. Okay, so this is called actually co-reference resolution, because nowadays if you see the ChatGPT, Gemini, so these kinds of application is able to understand, okay, this kinds of input, this kinds of prompt. Okay, so in the backend actually they're handling like that. I hope it is clear now. Then the third actually step were available inside Generative AI pipeline, which is nothing but feature engineering. Feature engineering. So inside feature engineering, you can perform text vectorization. So to perform the text vectorization, you can follow some technique like you have TF-IDF, you have something called bag of word, you have something called word to vec. You can also perform something called one-hot encoding. Then you can also use some transformers model to perform the text vectorization as well, because these are the very old technique. So if you're using any deep learning and machine learning model, that time you can use these are the technique. But if you are creating advanced application, like let's say if you're using large language model, transformer based architecture, let's say encoder and decoder architecture, that time you have to use transformer model to perform the text vectorization technique. Okay, I hope it is clear. So these are the steps that are available inside feature engineering. So inside feature engineering, you will just try to convert your text to vector representation. It can be also work with the image as well. Let's say you are having an image. Okay, let's say you are having an image, and in that image actually you are having a cat image. Let's say this is a cat. Let's say this is a cat. Okay, now image is nothing but it's a pixel. So if you just see the image, so here you will see different pixel value. Okay, different pixel value. So that time what you can do, you can use any kinds of vision transformer model to convert this image to the vector representation. Okay, vector representation, and you can pass to the model. Okay, so that is the idea. Now fourth step actually I think you saw. After feature engineering, you can do the modeling. Okay, modeling. Modeling means you'll be training the model. That means you'll feed the data to the model. Okay, so here you can choose different model. You can choose actually different kinds of model. So here you can either use open source. Okay, open source LLM, that means large language model. Either you can use paid one. Okay, paid model. So what is the difference between open source and paid? See, if you're using paid one, this model would be available in the server. That means you don't need to download this model in your machine. Okay, so you don't need to download. Instead of that, what you will do, you will only, let's say, pass the data. Okay, let's say you are using OpenAI, because I think you know OpenAI provides actually paid model. That's a GPT model. So in OpenAI, you will upload your data, and in their server, it will train the model. Okay, you don't need to download the model in your machine, and you don't need to train there, because I know that people won't be having good GPU in their system. Okay, it's not possible actually to buy expensive GPU for training these kinds of large language model, because if you see this large language model, it's very huge. Okay, if you see the parameter size is very huge, so we can't download in our machine and we can train it. It's not possible. So that's why most of the time we'll be using cloud platform to train the model. Okay, so that time actually we can use the paid model, because paid model, if you're using paid platform, if you're using everything, they will take care. Only you have to upload your data there. But if you're using open source large language model, that time you have to download this model in your machine. You have to prepare everything. You have to set up the environment, and then you have to train the model. And for this, you need a good GPU. Okay, good GPU, good CPU, good memory. Okay, everything you need. And after training this model, you have to deploy this model in a cloud platform. Okay, manually you have to deploy this model in a cloud platform, and again you will get the challenges there. Like you have to buy a good instance, then you have to set up the load balancing and all. Okay, then you have to deploy this particular model. But if you're using cloud platform, they directly will get one option to deploy the model in their server only. Okay, so that people can access the model in their platform only. Okay, so you don't need to take care about the infrastructure. You don't need to take care about the instance. So everything they will take care. That is the difference. Got it? We'll be also understanding how we can use paid model, how we can use open source model. And I will also discuss the difficulty level actually you will be getting whenever you will be using open source LLM, whenever you will be using, let's say, paid LLM. Everything I'll try to clarify. No need to worry. Training your model, you have to perform something called model evaluation. Okay, evaluation. So inside evaluation, you have to perform two kinds of evaluation. One is like intrinsic evaluation, and that is like extrinsic evaluation. So intrinsic evaluation means you'll be using some metrics. Okay, you'll be using some metrics to evaluate the model. I think you know we are having different metrics for the evaluation. Let's say we are having accuracy score, R2 score, then we are having AOC curve. So these are the different metrics we are having. Okay, so after training a model, you have to perform something called intrinsic evaluation, and this is performed by this evaluation will perform by the GenAI engineer. Okay, GenAI engineer, because they are training the model, and after training the model, they have to actually evaluate the model with the help of these are the matrices. And the extensive evaluation when they have to perform after doing the deployment. Okay, after doing the deployment. So this evaluation can be applied during the production. Okay, let's say whenever this model is in the production, people are using it. At that time, this extensive evaluation can be performed. Let's say I already told you, ChatGPT will launch one input. Sometimes it will ask you give the feedback. Not only ChatGPT, if you see any kinds of application. So if you just consider your phone keyboard, so whenever you use the keyboard, okay, so initially I think you won't be getting any kind of suggestion, but whenever you will be using that particular keyboard, okay, long time, then you will see that automatically you will get the suggestion, because it is learning. Okay, what kinds of input you are giving, it is learning, and sometimes it will ask for one kinds of feedback, whether you are enjoying this app or not. Okay, any feedback you want to give or not. And whenever you are giving the feedback, whenever you are giving the 5 rating, 4 rating, that time actually they are getting this application is working fine, there is no issue. But whenever you are giving negative feedback, that time they're getting actually there is some issue with the application. That time what they will do again, they will retrain the model. Okay, they will retrain the model, and they will again push the model through the production. Okay, so that's how extensive evaluation works. That means after deployment, after going to the production, okay, after going to the production of that model, you will be performing this particular extensive evaluation. This is the idea. And the 6th, I told you, we have to perform deployment. Okay, deployment. And inside deployment, you will be also doing the monitoring and retraining. Okay, retraining, because you will be doing the monitoring in the extensive evaluation, and if something going wrong, you'll be doing the retraining of the model. This is the idea. So these things are involved inside. So the entire generative AI pipeline, I hope it is clear. So first of all, data acquisition, then data preparation, then feature engineering, modeling, evaluation, and deployment. And here one thing you have to remember, because going forward I'll be using this term a lot. So let me just write here a common term. Let me copy this text and let me paste here. Let's say this is my data. Now here you will see some of the actually, let's say, common term. The first term actually will see called corpus. Okay, corpus. Then the second term you will see, which is nothing but vocabulary. And the third term you will see, which is nothing but documents. And the fourth you will see something called word. Okay, word. Now what is corpus? Corpus is nothing but the entire text. Entire text. That means the entire text is called corpus. Okay. And what is vocabulary? Unique word. Unique word. Now you can see this is unique word, this is unique word, this is unique word, this is unique word, this is unique word. Okay, so these are the what is unique. And if you see any of the word is coming duplicates, only you have to take the unique word. Okay, this is called actually vocabulary. Okay, then what is documents? Document is nothing but one row. That means one line only. So till here actually one documents, D1. Then this is called actually D2. Okay, D2. Then D3. So this is called actually documents. So I can write one line. Okay, one line is the documents. Okay, or one row. And what is word? Word is like thus single word. Okay, single word is called word. So you can see this is a single word, this is a single word, this is called actually word. So these are the common term you have to remember, because going forward, whenever we'll be actually playing with the data, that time actually I may tell you these are the actually common term. Okay, that time you won't be getting confused. What is corpus? What is vocabulary? What is documents? What is word? Okay, that's fine. So that's why I showed you. Okay, here in this video. So yes, guys, these are the actually generative AI pipeline, and here I have just showed you as a theoretical. So in the next video, we'll be doing the practical of it, like how we can perform different text cleaning technique, like different text preprocessing technique. After that, we'll also see how we can perform feature engineering technique as well. Okay, different feature engineering technique. Because what I feel like, before starting with our large language model, first of all, we have to understand the data. First of all, we have to know how to prepare the data for the model. Okay, then we'll be starting with the large language model. Okay, so this thing actually is So this thing actually very important before learning your generative AI, before learning the large language model and application building. So that's why I'm teaching you this part. In our previous video, I already discussed about end-to-end generative AI pipeline. So there I told you what is the use of data pre-processing, right? Because if you want to use the model, that means large language model, the first thing you have to do the data pre-processing, because unless and until you are not processing the data, how your model will try to understand that one, right? That is the idea. So here we'll be learning various kinds of technique to clean up our data. So for this, what I have done, I have created a beautiful collab notebook. So there actually I have added all the examples you can use for the data cleanup operation. So guys, now let's try to see how we can do the data pre-processing part. So guys, as you can see, this is the notebook I already prepared. So here you can see I'm using one dataset from Kaggle. So let me open the link. This is the link. So the dataset name is IMDb dataset, and it is having actually 50k movie reviews. Okay, 50k actually movie reviews. If you are already from, let's say, machine learning, deep learning background, I think you know about this dataset, right? It's like very common dataset. And why I took this particular dataset, because in this dataset you will see there are so many actually unnecessary text. Okay, because it's a movie review. So what they did actually, they extracted, they scrapped this data from the IMDb website. If you don't know, this is the IMDb website, IMDb. So in this website, you will see all the movies, reviews and rating. And what they did actually, they published this dataset in the Kaggle website, so that if anyone is working in the field of, let's say, generative AI or natural language processing, they can use the dataset. Now here, what you just need to do, you just need to download this data. Okay, it's around, I think 27 MB. Just click on download button, it will download. Okay, so I already downloaded this dataset. So it is available inside my download folder. So I'm going to upload in my collab notebook. So here, first of all, what you have to do, you have to connect this particular notebook. So there is a connect button, just try to connect. And no need to worry, I will also share this notebook link in the resources section. From there, you can open it up. So my notebook is connected. So first of all, let's import some of the library. First of all, I need something called pandas, because if you see the data, it's a CSV data. Okay, it's a CSV data. So let me upload and let me show you. So if you want to upload anything in the Google Drive, just try to right click and there is an upload button. Click on upload and try to upload this data here. Now see, it's a CSV file. Okay, and if I want to load any kinds of CSV file, JSON file, or let's say Excel file, whatever file, you can use the pandas package for that. So you can see my dataset is uploaded. Now if I want to load the dataset, what I have to do, I have to assign the path. And see, you don't need to execute this at the code, because this code I have added. Let's say if your dataset is available in your Google Drive, that time what you have to do, you have to mount your Google Drive. First of all, mount means you will be connecting with your Google Drive, then we'll be relocating the folder. Okay, like inside which folder you kept your data. Okay, with the help of cd command. Cd means change directory. Okay, then after that, what you will do, you will assign the data path. But here I haven't kept my data inside my Google Drive. I kept inside my collab. Actually, you can see drive. This is the collab disk I'm using. Here you will get around 74 GB of space. So here you also you can keep your data. So I don't need to execute this code. What I will do, I'll just go below. And if I check my current working directory, that means pwd, you will see I'm inside content. Content means this is the directory right now. Now here, I'll just simply define my data path. So I'll copy the path, copy, and let me paste it here. Okay, that's it. Now let me execute. Now see, if I now load the data, pd.read csv I'm doing. So now see, it will load the data. See, it has loaded the data. If you want to see the shape of the data, this is the shape. Okay, you have around 50k actually movies reviews in this particular CSV file, and two columns. Two columns means one is the reviews column, another is like the sentiment column. Okay, sentiment means whether it's a positive sentiment, whether it's a negative sentiment. This kinds of sentiment you will get here. I hope it is clear. Now see, here I'm having 50k movie reviews, but here I'm not going to use all the reviews. Here I'm going to show you the demo, like how we can perform the text pre-processing. And if I'm taking all the 50k reviews, so it will take like lots of time to process those at the text. So what I will do, I'll only take the 100 example. Okay, the first 100 example I'll be taking, and on top of that, I will perform all the text processing task, right? So this is the code you can execute. So it will load 100 example. Now if I show you the shape, see, now we are having 100 example and only 2 columns. Fine. Now if I want to show you the data, see, this is the data. So I think you remember in my theoretical class, I was discussing about some pre-processing technique. Here I think So here you can perform something called HTML tag removal, emoji handler, then spelling correction. Then in the basic preprocessing, we saw that we can perform something called tokenization. Then we had some optional preprocessing as well, like stop word, streaming, lemmatization, punctuation, lowercase, okay, language detection, each and everything. So first thing we'll be learning how we can perform the lowercase operation. And why lowercase is important, I already explained here. I think you remember. Let's say if one of the name is containing uppercase character, it will consider these are actually separate name. Okay, these are actually separate entity. That is the idea. So that's how we have to bring everything in a lowercase character. So that's why you have to apply this lower operation. And how to perform lower operation, I think you already know. In Python, we are having a function called lower. With the help of lower also we can do it, right? Now see here, let me show you one example. Let's say I'm taking the reviews 3. So here I'm taking the three number rows. This is the 3 number rows. Now you can see some of the character is uppercase character here. So this is uppercase, this is uppercase. Okay, so that's how actually you will see different uppercase character would be there. Now if I want to make them lowercase, what I have to do, first of all I have to select my column, like in which column you have to apply the lower function. I have to apply on top of my review column. Now first of all I'm converting everything to the string, okay, string data type. Then I'm applying the lower, because lower is a string method. Okay, lower is a string method, I think you already know that. Then whatever changes actually I'm doing, I'm saving inside my column. That means I'm just doing the permanent change, okay, inside my column. So that's why I've given a review again. That is the idea. Now if I execute, now see if I show you the data. Now see guys, all the character has become lowercase right now. Now if I want to show you the, now if I again execute that review 3, you will see that all the character has converted to the lowercase character. Okay, that is the idea. Now the next thing we'll be learning how we can handle the HTML tags. That means how we can remove the HTML tags. For this, here I have written a function. Here I'm using something called regular expression, regex. Okay, so inside regex you can give a pattern. Let's say here you are giving a pattern. If you are getting this kinds of symbol, okay, if you are getting this kinds of symbol, it's a like HTML tag. You have to remove those HTML tags and you have to replace with empty. Okay, empty string. That is the idea. Now this is the function we can use. Now if I execute, now let's say this is a one text I have prepared. You can see in this text actually we are having lots of HTML tags. Now if I pass this particular text to my function, see, it will automatically remove all the tags. Now see, I'm only getting the text, okay, relevant text. That is the idea. So this notebook I prepared in a such a way so that you can use it as a template. Let's say whenever you need anything, any kinds of functionality, you can come here, you can copy those function. So please try to keep this particular notebook with you, because this is going to help you a lot. Okay, whenever you'll be developing the projects, this is going to help you a lot. Now, if you want to apply on top of the entire data set, again, just call this column name, let's say review column. Okay, and there is a function called apply. And inside that, just try to pass this function. Okay, apply function takes actually one function object. Now here I'm giving the function object. So what it will do, it will try to apply this particular function on top of the entire rows you are having in your data set. Okay, now see if I execute, and the changes actually I'm doing, I'm saving everything permanent. Okay, now let me execute. Now if I show you any kinds of random, let's say rows, now you'll see all the now let's see if I also show you 7 number rows. Now just try to see, there is no HTML tags in this particular text. You can pick up any kinds of, let's say index. So let's say if I show you the 10, nowhere you will see the HTML tags here. Now we'll be learning how we can remove actually URL. Let's say if you are having some URL in the text, how we can remove it. For this, again, I'm using regular expression, and there is a pattern I have given. If you are getting this kinds of, let's say a word HTTP, then slash, then www, that means it is a URL, and you have to remove the URL with the empty string. Okay, this is the function. Now let me execute. Now here I have just mentioned some of the URL. So this is my YouTube channel URL, this is my LinkedIn URL, and google.com and kaggle.com. Okay, now these are the text I have prepared one by one. Now let's say if I'm passing any kinds of text inside my remove URL function, it will remove that URL. Let me show you. See, I'm giving the text to, that means my LinkedIn URL. Now you can see, check out my LinkedIn. I hope it is clear. See, again, I'm telling you, it's not a mandatory things. Let's say you need URL in your data. At that time, you can keep it. Let's say you need actually HTML tags. You can keep it. But if you don't need it, you can remove it. Because I already told you, nowadays actually we are having advanced generative AI application. It also supports all kinds of text like emojis, HTML, okay, everything it supports. So if you are creating these kinds of advanced, let's say, application, that time you need these are the data. You don't need to remove it. Okay, but sometimes actually you also need to remove this data set. So that's why I'm showing you how we can remove it. And if you want to keep it, you can also keep it. It's up to you. Okay, you have to decide based on your project architecture at that time. This is the idea. Now we'll be learning how we can handle the punctuation. So if you want to see the punctuation, so there is a string package you can use. Now if you just write string.punctuation, you will see all kinds of punctuations are available. Now what I have done, I just stored these are the punctuation in a variable called exclude. Now here I have written a function. Okay, here I have written a function called remove punctuation, and here I have written a for loop. So I'm just looping through this punctuation one by one, and user is giving the text, and I'm just checking whether if there is any punctuation. Okay, I'm just replacing with the empty string. Now let me show you how it will work. Now let's say this is one text string with a punctuation. You can see there are so many punctuation I have assigned. Now if I pass this particular text to my punctuation functions, it will remove the punctuation. Now see, there is no punctuation right now. Even I'm also calculating the time, like how much time it is taking to remove the punctuation, because there is another way you can follow to remove the punctuation. I'll tell you how you can do it. See, this is the function, guys. So here you can use something called text.translate. Inside that, just try to use this particular function. Okay, make translate, and inside that just try to mention the punctuation. So what it will do, it will take your text and it will remove all the punctuation. So this is another approach. Now see, if I calculate the time of this function, you will see that this is the time. That means this function is taking less time than your this function, because here you are using one for loop, and for loop has the linear time complexity. I think you know that. If you are familiar with DSA concept, I think you know that it is having linear time complexity. Okay, so this particular approach is good. So let's say if you are applying this particular logic on top of 50k data set, just try to think how much time it will take, this for loop. And in other hand, if you are using this particular method, it will take very less time to perform the operation. Now if you want to see the time difference, you can also see the time difference. Now if I show you my text, now see, inside this text actually I'm having lots of punctuation. Now what I will do, I will use my remove function one, that means this particular function, and inside that I'm going to pass my entire review. Now see, it will remove the punctuation. Okay, see, all the punctuation has been removed. Now you can also pass the entire data like that. You can also pass the entire data. It will remove all the punctuation inside your entire data. Now we'll be learning how we can handle the chat conversation. See, sometimes whenever we perform the chatting operation, we give like lots of shortcut. Let's say if I want to write as far as I know, what you will give? You will give AFAIK. Then let's say away from keyboard, AFK. Then as soon as possible, ASAP. That's how we use lots of chat keyword. Okay, we use lots of chat shortcut keyword. Okay, here I have listed down some of them. You can see for your information, FYI. So that's how I have listed all the chat conversation short word. Now let's say you are working with actually social media dataset. In the social media dataset, you will see these kinds of data a lot. People will be using short form. Okay, short form. So how we can handle this particular short form? For this, first of all, try to create a dictionary like that. The entire dictionary you have to create. Then after that, here I've written a function. So this is the function chat conversation handle. So inside that, I'm just taking the text. Okay, I'm just taking the text and I'm checking. And inside that, with the help of this for loop, I'm checking if we are having these kinds of word. Okay, if you are having these kinds of word, what we're doing, we're just mapping with the value. That means, let's say, if anyone having actually this particular, let's say, a shortcut word, let's say FYI. What I will do instead of FYI, I will just return for your information, because this is a dictionary. If I want to get the value, I want to call the key. Okay, that's how we are mapping. Now see, if I execute the program. Now let's say here we are giving a short message, do this work ASAP. Now see, it will return me, do this work as soon as possible. Okay, because here it is coming here and it is mapping and it is giving me this value. Okay, this is the idea. Now let me see how we can handle the incorrect text. Let's say sometimes what happens whenever you are using real-time data, there would be lots of spelling mistake, right? Let's say this is one example, certain, so certain spelling is not correct, then condition spelling is not correct. That's how you will see different word is having the spelling mistake. So how to handle this spelling mistake? For this, you have to use one package called text blob. So let me import this text blob. And now see, here I'm having one incorrect text. Now if I pass this incorrect text to my text blob, and if I call this particular function called correct, now see, it will handle everything. Now see, certain conditions during several, see, all the word has been corrected. So this is one amazing package you can use if you want to handle the spelling. Okay, spelling of any word. Now the next thing we'll be learning how we can handle the stop words. So inside English language, not only English language, inside all kinds of language, we're having some stop words. Okay, now here we're working with the English language. So let me show you some English related stop words. For this, I will be importing stop words from the NLTK. NLTK is nothing but it's a natural language toolkit library. So with the help of NLP also, you can perform lots of NLP related tasks. So here you can see I'm importing the stop word. So here I'm performing NLTK.download. It will download all the stop words from the internet. Now see if I click this cell, it will download the stop words. Now, if you want to list down all the stop words, you can just write stop words dot words, and here you can specify the language. So here I'm working with the English language. So here I've given the English. Let's say you are working with Hindi, Bengali, you can give that language also. It will give you the stop word related that language. So you can see the documentation of NLTK. We'll see that how we can pass the parameter here. Now see, these are the words we are having inside English. So this is called stop word. So this word doesn't have any kinds of meaning, okay, in a sentence. Okay, we use it to represent one sentence, but there is no meaning. So let me show you why I'm telling there is no meaning. Let's see if you want to perform sentiment analysis. So let's say there is one review we are having. So let me just write, this movie is awesome. I loved it. Now just try to see, here you are having some stop word, right? Like is there, this is there, I is there, it is there, right? But if I want to get the sentiment of this particular, let's say reviews, I can see movies is required, awesome is required, loved is required. Now if I'm getting these kinds of word, actually this kinds of positive word, that means it's a positive sentiment. Okay, it's a positive sentiment, yes or no, right? So here actually I don't need these are the stop word. Okay, I don't need this as the stop word to understand whether this particular reviews is a positive or negative. And if you're using these are the stop word in the sentence, what will happen whenever you will perform the text vectorization? It will make actually extra dimension. Okay, it will make the extra dimension in the data. And whenever it is making the extra dimension, that means if dimension is increasing, that time your model might get difficulties, right? Because we know that there is a concept of curves of dimensionality. So we always need to reduce the dimensionality somehow. I think you have learned in your machine learning. Okay, machine learning, let's say topic. So that is why we don't need these are the stop words. So we have to remove this particular stop word sometimes, and sometimes actually we have to also keep it. So these are the stop word, guys, you saw. Now let me show you the length. So around we are having 179 stop words present inside English. Now here I've written a function. So this function will remove the stop words from a text. Now let me show you. Let's say this is a text I have given. So inside that you can see different stop words are there. Now if I pass to my function, so see, now see, there is no stop word in this particular text right now. Okay, that's how you can use this particular function. Now again, this is my data, and if I want to apply on top of my entire reviews, I can do it. I can use the apply function, and I can pass my function object, remove stop words. And if you want to store permanently, what you can do, you can write this code. Okay, df reviews is equal to df reviews apply stop words. Okay, it will save everything permanent, but I don't want to save it permanent as of now because I'm showing you as a demo. If you want to do the permanent, you can do it. So now guys, I think it is clear how we can remove the stop words. Now the next thing we'll be learning how to handle the emoji. Okay, see, emoji is nothing but it's a Unicode actually character. Okay, if I show you, if you just write emoji Unicode, you will see different Unicodes of different emojis. So let me open it up. See, here we are having different emojis. Based on that, we are having the Unicode. Okay, Unicode character. Okay, Unicode character. So that's why I just collected some of the Unicode character, like for the emotions emojis, symbols, then pictographs. Then we're having transport, map, symbol, flag. Okay, so these are the emojis related Unicode I collected here, and I just written a function. Okay. And again, I'm using the regular expression. So here I'm telling if you are getting this kinds of Unicode in a sentence, that means it's an emoji. So what you have to do, you have to remove those emoji with the empty space. Okay, now let me show you. So let's say this is one text I'm giving. Love the movie, it was flying kiss. Okay, now see if I pass this particular text, now see it will remove the emojis automatically. Now this is the next one. Now see, only Llama is coming. Now sometimes actually I told you emojis are required. Because let's say I told you in the ChatGPT example. So if you pass any kinds of emoji to the ChatGPT, it will also able to understand, okay, what you are trying to say. Let's say if I pass any kinds of emoji here, let's say I'll give this emoji. Hey there, what's on your mind today? See, it is trying to understand my feelings, right? Now, if I want to handle these kinds of situations, what I have to do, I have to keep the emoji. That time, what I can do, I can extract the meaning of the emoji. So for this, I can use one library called emoji. Okay, now let me show you. First of all, you have to install it. Now just import the emoji, and inside emoji you are having one method called demojize. Okay, now inside that just try to pass the text Python is fire. I'm giving the fire emoji. Now see, it will automatically convert to the word Python is fire. Okay, that means it is trying to extract the meaning of that particular emoji right now. I hope you cleared. So that's how whenever you are passing any kinds of emoji as an input to the ChatGPT, it is trying to convert this emoji to the word and is trying to understand what you are trying to say. Now there is another example I have given. I love this movie. It was flying kiss. See, love this movie. It was face blowing a kiss. Now we'll be understanding the tokenization. I told you we are having two kinds of tokenization: sentence level tokenization and word level tokenization. So let's try to see. See, if you want to perform the tokenization, directly you can use the split function, because the split also will give you the individual word in a list. See, if I have one sentence, now if I perform the split operation, see, I'm getting actually individual word. So with the help of split also you can perform the tokenization. So similar wise, you can also do the sentence level tokenization. This is the word level tokenization. Now for this, you have to mention this particular full stop sign. So whenever it is getting the full stop, that means this is one sentence. Okay. Now see, if I execute, so here I'm having 3 sentences. So I am going to Delhi. I will stay there for 3 days. Let's hope the trip to be great. Okay. See, 3 sentences I'm getting. So this is called sentence level tokenization. So again, some of the example with the split function. Now with the help of regular expression, you can also do the tokenizations. So this is one example I kept with the regular expression. So here is my sentence and it will give you the individual word. This is the sentence level tokenization. Okay. And this is the pattern for the word level. This is the pattern for the sentence level. Okay. This is the idea. Now you can also use something called NLTK. Okay. That means Natural Language Toolkit Library for the tokenization as well. Inside that, we are having two actually function: word level tokenizer and sentence level tokenizer. Now let me, and if you want to perform the tokenization, you have to download this particular thing called PUNKT. Okay, this particular thing you have to download. Okay, now see, here is my sentence and I want to perform word level tokenization. I will pass this, so it will give me the word level tokenization. So automatically this function will handle. Now if you want to perform sentence level tokenization, you can use sent tokenizer. Okay, from here, and you are getting the sentence level tokenization. Okay. So again, some of the example you can try, I have given, and I created this notebook in such a way you can use it as a template. I already told you I have written like the function wise, right? If you need any kinds of, let's say, cleanup technique, you can copy from here and you can use it in your code. That's the idea. Now there is another package you can use called Spacey. With the help of Spacey, also you can perform the tokenization. Fine. So you can explore this part. Now let me go to the schema. Okay, I already told you what is schema. Schema means you are trying to bring the different word in a root form. That means let's say you are having play, playing, played. So what you will do, you will apply schema and you will just try to convert it is to the, and you'll just try to convert to the root word, that means play, right? Because it is meaning the same, okay, in a sentence. So now let me show you. So inside NLTK we are having this schema, porter schema. Now we are importing porter schema, and here we have created the function steam word. So whenever you will give any kinds of, let's say, sentence, it will perform the steaming operation. Now see, here I'm giving work, works, walking, work. Now if I give this particular sentence, it will give me the root form. That means work, 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 and all. Okay. Now see, here I kept one sentence. So this is the entire sentence you can see. Now I want to perform steaming operation on top of the sentence. So I'm using my function. Inside that I'm passing the sentence. Now see, it will give me the steaming word right now. Now see, probably it has been probable. Okay, probable. That's why I told you steaming is not readable. Sometimes you will get some kinds of word, it's not readable, but your model will try to understand. Okay, but as a human, it's not readable. See, favorite has been converted to favorite right now. Okay, so in case actually what you can use something called llamatization. Okay, llamatization will handle this kinds of situation. It will give you a readable word actually. Now see, this is the llamatization code. So it is available inside NLTK. I'm importing the llamatization, initializing the llamatization, and if you want to use llamatization, you have to download these at the things, WordNet and OMW. And now if I execute this code, you will see that it will give you the llamatization for all the words. See, so this is the word, this is the llamatization, this is the word, this is the llamatization. Now see, it's readable. Okay, it's readable than your steaming one. I hope it is clear. Fine. So that's why I just written steaming and llamatization are same to retrieve root words, but llamatization is good, llamatization is slow, and steaming is fast, because llamatization will give you the readable output. That's why it's a little bit slow than your steaming. Okay, I hope it is clear. So yes, these are the technique you can follow for the text pre-processing. If you are having any kinds of text, you can perform text pre-processing with the help of these are the technique. You can clean up your text. Okay, and again I'm telling you, it's not required to perform all the text cleaning technique. Sometimes if you need anything, just try to keep it as it is. That is the idea. Fine. So yes, this is all from this video. And what you can do right now, you can download any other dataset from the kaggle.com, because Kaggle is having different dataset, not only movie dataset. You will also get something called Twitter dataset. I think Twitter dataset is also available. See, Twitter dataset is also available. Just try to download the Twitter sentiment dataset and try to apply. These are the text preprocessing on top of the Twitter dataset. Okay, so this should be one task, guys, from my side. Please try to attempt, because unless and until you are not practicing, things would be more complicated. And whenever you will be doing the practical, okay, by yourself, things would be more clear here. So in the next video, we'll be learning how we can perform the data representation. That means text representation, how we can vectorize our text. That means we'll be converting our text to numbers, okay, for the model. So I think you already know what is data representation. That means inside generative AI, you will be working with textual data. So not only textual data, you will be also working with something called image kinds of data. Now, these are the actually raw file. If you see any kinds of text data, any kinds of image data, okay, so these are actually raw data. These are actually unstructured data. So I can't directly pass these kinds of data to my model, because model is nothing but at the end, it's a mathematical equation only, right? And mathematical equation can only support numerical data. So what we have to do, whatever text data, whatever image data we are using here, we have to convert them to the vector. That means we have to convert them to the number, okay, numerical representation. So this concept, we call it as a data representation. You can also call it as a data vectorization. Okay, so here we'll be seeing couple of technique we can follow to perform these kinds of vectorization technique on top of our data. Even I will also show you some drawbacks with different technique, and which technique actually at the end you have to follow for the generative AI. If you're working in the generative AI, if you're working with the large language model, so which technique would be suitable for your task. Okay, so here everything I'll try to clarify. So please try to watch this video till the end. And if you have any kinds of doubt, you can also ask me in the comment section. So let's start, guys, with our data representation topic. So guys, in this video, I'll be discussing about like what is feature extraction from text. You can also consider as image. Then we'll be discussing about why we need it. Then third, I'm going to discuss why it is so difficult. Then we'll be discussing about what is the core idea and some techniques. So this should be my entire video agenda. So first of all, we'll be discussing about what is feature extraction from text. You can also consider as image, because I told you na, in generative AI, you can use any kinds of data, whether it can be text, image, audio, okay, anything. See, first of all, we have to understand what is feature extraction. See, feature extraction is nothing but, let's say you are having a unstructured data. Let's say you are having a text data, or let's say image data. So from this data, you are extracting some features to represent that particular data. So I think those who are already familiar with computer vision, you already learned about convolutional neural network. So with the help of CNN, what we can perform a feature extraction. That means we just try to extract some of the features from an image. So what kinds of features? Let's say the edges, okay. Then you'll be also extracting some patterns. So these are the actually features. So with the help of these particular features, my model will be able to understand about the data, and it will be able to predict something, okay, on top of the test data. So this is the idea. So in generative AI also, what kinds of data actually we're using, we also need to perform something called feature extraction, because whether it can be text data, image data, any kinds of data, the first thing what you have to do, you have to extract the features from that particular data. Okay, this is the idea. And feature extraction means you are converting your textual data to numerical representation. That means to the vector representation. Okay, this is the idea. Then the second thing actually you can see why we need it. Because as I already told you, in generative AI, whatever model you are using, whatever large language model you are using, every model is a mathematical equation. And mathematical equation can't take actually your textual data or image data directly. So for this, definitely you have to convert to the number. Okay, numbers. You can also call it as a vector. Okay, vectors. So if you can convert to the numbers or vectors, then your model will be able to take this particular data as an input, and it will learn, okay, what kinds of actually pattern it is having. Based on that, it will try to generate something. This is the idea. Okay. Now, why it is so difficult? So whenever I'm talking about text data, okay, whenever I'm talking about text data, it would be a little bit difficult for you to extract the features from the data. Why? So let me show you some example. Let's say if I'm considering, let's say ML in machine learning, I think you remember inside machine learning, what kinds of data we used to use? I think you remember we used to use something called tabular data. Okay, tabular data. Tabular data, like we used to use something called CSV data, then Excel. Fine. So these are the actually tabular data. That means here you will have a table. So let's say this is your table. So it will have one fixed table. So in this table, you will have the fixed column size. Let's say you are having here 1, 2, 3, 4 column and some of the rows. So 1, 2, 3, 4 columns. 1, 2, 3, 4, 5 rows. Okay. So here your table dimension is 5 cross 4. Okay. So this is the table dimension. That means it's a fixed size. It's a tabular data. Okay. It's a tabular data. So here you will have the column. Okay. Here you have the column. And here you will have the row. I hope you cleared. Now you will store the data. Fine. Now, whenever you are taking any kinds of, let's say, machine learning model, let's say this is your machine learning model, your ML model. So what you will do? So so what is the X feature size? X feature size is nothing but your input size. Okay, input size, that means the independence variable. Let's say you are doing house price prediction. So let's say this is number of room. Let's say this is the area of the house. Let's say this is number of bathroom. And this is the price of the house. So this is your Y variable. Okay. And these are your X variable. Okay. So X variable, I'm having how many? 1, 2, 3. 3 X variable I'm having. Okay. That means you will give 3 input to the model and only 1 output you will get, which is nothing but Y hat. Okay. This is the idea. That means to the model, you have to give X data 3 column and Y data 1 column, which is nothing but your price. And this is your target variable. Okay. And once you pass the data, you will get the output. That means here your column size is fixed. So here what you saw, your column size is fixed. That means your input size is fixed. Okay, to the model. Okay, there is no issue. That means we can easily use our tabular data. Okay, for in the machine learning, or you can also use in the deep learning. For this, you have to use something called neural network. That means artificial neural network, right? Now let's consider image data. Let's say inside computer vision, we use something called image data. Okay, image, videos. And whenever I'm talking about videos is nothing but it's a frame of image, right? It's a sequence of image. So you can convert videos to image, then you can analyze, again you can convert to videos. So let's consider image only here. So let me show you. See, image is nothing but it's a pixel. Okay, inside image actually we'll see different pixel values. So let me show you one example. So guys, here you can see here I kept one image, and this is a MNIST digit image. So here you can see 3 has been written. So if you just zoom this image, what you will see these kinds of pixel. Okay, and inside pixel you are having different numbers. You can see these are actually numbers. So this number range would be 0 to 255. Okay, 0 to 255, this is the range of the number. And one thing, wherever you can see the 0, okay, 0 number, you can see it's a white pixel. Okay, it's a white pixel. And whenever you see some number, okay, it's a black pixel. You can see whenever you can see much darker color, it's that means it is close to 255. And whenever you see some mild like darker color, that means it is close to 0. Okay, so this is the idea. Let's see, your 3 looks like that. Let's say this is the 3 in this image. And here is the 3 representation in the number. That means if you zoom this image, you will see some numbers, that some value, pixel value would be there. Okay, so that's how actually your 3 looks like. So whatever image you are taking, you'll be getting this kinds of pixel value. Okay, at the end. Now whenever I'm talking about image data, so you can easily convert image to a table representation because it's a pixel value at the end. So what you can do, you can create a fixed table. You can create a fixed table. Let's say this image dimension is 28 cross 28. Okay, now just try to calculate the pixel value. Based on that, just try to create the table and add all the number here, add all the pixel. Now if you calculate all the pixels here, so if you just multiply 28 cross 28, you will get something called 784. Okay, I think that many of pixel. So this should be your input size. Okay, this should be your input size. Now what you can do, you can create a neural network. Okay, dot 784. Now just pass all the data one by one. Okay, pass all the data one by one and so on. Okay, till 7 84. Okay, so that's how again you can create a easy neural network. And here input size is also fixed, which is nothing but this is the input size, because all the image will have the dimension, fixed dimension. Okay, I hope it is clear. That means there is no issue with the input size. Now the next data, let's talk about audio data. Okay, audio data. So audio is what? Audio is nothing but, so what is audio? Audio is nothing but it's a frequency. You can see it's a frequency. So whenever you will see some audio, you will get this kinds of frequency response, and the parameter of the audio would be dB. Okay, that means decibel. Okay, this is the frequency of the audio. Now you can easily convert this audio signal to a number representation, because here you can see, let's say this is your hertz. Okay, this is your hertz, frequency hertz, and this is your dB, that means decibel. Like, and now you can see this is the actually frequency. Now just try to see the graph, and based on that just try to collect the number. Let's say you have created one table. Let's say this is your table. So one column you just consider, let's say this is the frequency and this is the decibel. Okay, dB. Now just try to collect the data. Let's say here you can see 400 hertz and the decibel value was, let's say, minus 10 dB. Okay, that's how just collect all the data. Okay, collect all the data. Now again you will see we'll have one fixed table. Okay, we'll have one fixed table. Again you can take a deep learning model here, let's say artificial neural network, and you can feed the data. You can feed the data and you can get the prediction. Okay, again you don't have any issue with the input size. But whenever I'm talking about, let's say, text data, whenever I'm talking about text data, so here you will get the difficulty. How? So let me show you. So let's say this one sentence I'm having, my name is Bappy. So here just try to see how many tokens you are having. So we are having 1, 2, 3, 4. That means 4 tokens. Let's say somehow you converted this text to a number representation, that means vector representation. Let's say my you are considering as 0, name you are considering as 1, is considering as 2, and Bappy you are considering as 3. Now you will be creating a network. Let's say this is your neural network, 1, 2, 3, and 4. Then what you will do, you will feed the data. Let's say my will come here, name will come here, is will come here, and Bappy will come here. Okay. Now let's say you have taken some hidden neural network, and here you will get the y hat. Okay. Now let's say there is another sentence, how are you? Now see, here you will get the difficulties, because in the previous sentence, how many tokens I had? I had 4 tokens. Now if you count this sentence, you are having 1, 2, 3, only 3 tokens. Now let's say you have represented these tokens 4, 5, 6. Okay, let's say this is your vector representation. Now tell me, can I pass this particular data to the model right now? Because what is the model input size? 4. But here what is the input? You are having 3. So here you will get one dimensional issue. Okay, dimension issue you will get. Okay, so it will give you one error. So it is expecting 4-dimensional input, but you have given 3-dimensional input. Now just try to consider, whenever we write any kinds of text, it doesn't have any kinds of input length similarity. Okay, you can write anything. You can write, my name is Bappy, how are you? I'm okay. So it should be any kinds of length sentence. Okay, it can be any kinds of length sentence. And there actually we usually face the difficulty whenever we use this kinds of textual data, because it doesn't have any kinds of input size, because it's a completely unstructured data. And representing this text to numbers is very much difficult, because I can't assign 0, 1, 2, 3 like that. Because if you're assigning 0, 1, 2, 3 like that, your model won't be able to understand. It's not a meaningful number. But previously, the data I showed you, we can easily convert them to the numerical representation, because tabular data is already a numerical representation data, right? Then image is already a numbers, because at the end you are getting a pixel here. Then audio is already a number. You are getting a number here. But what about text? Text is a string. But how we can convert a string to a number representation so that it will have the same meaning of my sentence. Let's say here I have written, my name is Bappy. So after my name is coming, after name is coming, after is Bappy is coming. So with the help of number, how I can, let's say, contain that particular relationship? Is it possible? Yeah, it is possible, but it would be a little bit difficult for you initially, because you don't know like what kinds of, let's say, vectorization you can perform here to represent this particular sentence to a, let's say, meaningful representation. That is what I'm trying to say, right? So now you can ask me, sir, we can apply actually 2 techniques we have learned previously. I will tell you what kinds of technique we can apply. You told me, let's say the first technique we can apply something called one-hot encoding. One-hot encoding. So this encoding technique you have learned in your machine learning, right? That's whenever you have any kinds of categorical data used to perform this one-hot encoding, right? Then the second technique you can also perform something called bag of word. Bag of word. You can also call it as a bow, okay? Bag of word. So now let's try to discuss these two technique, how it can be applied and what are some drawbacks, okay, if I were applying these kinds of technique, okay? So first of all, let me discuss one-hot encoding. So what I'll do, I'll just create a table here. So let me create a table. So here I will take 2 columns and 4 rows. As of now, I'm only taking 4 examples just to show you, okay, how things will be working. But in actual way, we'll have more than actually 4 rows, okay? That means you might have thousands rows, let's say lakhs of rows, okay? It doesn't matter. Let's say this is your data 1. So here you are having a sentence, let's say people watch. Let's say I'll give my YouTube channel name DS with Bappy. So if you don't know, guys, this is my YouTube channel name. If you're interested, you can also visit. Then let's say data 2 we are having DS with Bappy much DS with Bappy. I'm writing any kinds of sentence, guys, as of now, whatever things I'm thinking in my mind. Now it's a data 3 you are having people write comments, and data 4 I'll be writing D4 DS with Bappy write comments. Okay, let's say this kinds of data we are having initially, fine. So that means how many rows we are having? We are having row 1, row 2, then row 3 and row 4. That means only 4 row we are having as of now. Okay, 4 example we are having, 4 data points we are having, right? Now if I want to perform one-hot encoding, so first thing what I have to do, I have to take the entire corpus, okay? And I already told you what is corpus. I think in my previous session, the text preprocessing session, at the last I was discussing about some like key important things you have to remember. Okay, so whenever I'm talking about corpus, that means your entire data. So just try to collect your entire data. Let's say people, then you have the watch, then you have the DS with Bappy, then you are having then again you are having DS with Bappy, DS with Bappy, then again watch, then again DS with Bappy, then you are having people, then write, then comments, then again DS with Bappy, write, comments. Okay, so this is your entire corpus. Okay, corpus. Okay, corpus of your data. Now from here you have to figure out how many unique word you are having. So we are having people, we are having watch, DS with Bappy, then write and comments. So these are the unique words. That means 1, 2, 3, 4 and 5. That means n is equal to 5. Okay, 5 unique word we are having. Now what we have to do, we have to create a table. Let's say I'll create a table with these 5 unique words. So the first word will come people. The second one will come watch. Then the third one will come, let's say DS with Bappy. Then write. Then comments. Okay, comments. Okay. So that's how your one-hot encoding will try to represent the data. Okay. Let's say whenever you are using any, let's say library in Python. So how this library works exactly to perform the one-hot encoding, that is what I'm explaining here. Fine. Now see how it will try to convert your text data to numerical representation. So first of all, it will take the row 1, that means D1, let's say people. Now just try to find people here. So you can see people is there, that means this should be 1 and everything would be 0. Okay, then watch. Now just try to find out the watch. So here is the watch, so it should be 1 and everything would be 0 again. Okay, then DS with Buppy, so it should be 1 and everything would be 0. Okay, so here the number actually we got, this is for the D1, that means data 1, row 1. So here I can write like that. That's, I'll just simply write D1. Okay, D1 is equal to, so here I got one 2-dimensional vector. So here 1 0 0 0 0. Okay, then comma 0 1 0 0 0, then comma I got 0 0 1 0 0. Okay, so this is my D1, that means sentence 1. Okay, this is for the sentence 1. Okay, I hope you clear. Now again you will take the sentence 2, that means D2. Okay, D2. Now you will just try to find the numerical representation. Now let's find the D2 as well. So let's say DS with Buppy. So again, let's say this one would be 1 and everything would be 0. Okay, so this is for actually D1, and now we are doing for D2. Now again it will see the watch. So watch is here, it would be 1 and everything would be 0 again. Now the next thing would be DS with Buppy again. So let's say this is a DS with Buppy and everything would be 0 again. Okay, so this is what actually your D2. So again I can represent like that. Let's say D2 is equal to 0 0 1 0 0, comma 0 1 0 0 0. Okay, then comma I'll take 0 0 1 0 0. Okay, so this is my D2. So that's how you have to complete for all the sentence. That's how you have to complete for all the sentence, and at the end you will get all the vector representation. Okay, you will get all the vector representation. I hope it is clear. Okay, how one-hot encoding can be applied. Now let's say you have completed for all the sentence and you got your vector. Now what you will do, you will just try to create a neural network. Now just see the input size. The input size for the model, you can see input size would be 1 2 3 4 5, because we are having 5 unique word only. So everywhere you can see 5-dimensional vector 1 2 3 4 5. That means you will be taking a neural network like that 1 2 3 4 and 5. Okay, inside that you will take some hidden layer and you will get your y hat here. Okay, so that means you will pass the data. Okay, you will pass the data in this particular layer. That means you will take this particular vector. So first of all you will do for the D1, you will take this particular vector, you will pass it here. Okay, then the second one you will pass it here, then the third one you will pass it here. Okay, that's how you will be passing for all the sentence. Okay, you will be passing for all the sentence. But let's say in case in your corpus, okay, in your corpus the number of unique word is 1000. Number of unique word is 1000. In that case, what should be the input size of the model? Definitely it will also become 1000s. That means you have to take 1-dimensional, sorry, 1000s neuron. Okay, at the very first. That means again complexity is increasing. Let's say in your entire corpus you are having 2000. Okay, 2000 unique word. So you have to take 2000 actually neurons. So if you're using one-hot encoding, that means the number of unique word you are having in that particular corpus, based on that your input layer would be decided. Okay, it's not a recommended, because if your input, if your let's say unique word is increasing, your neurons is also increasing, and whenever you are increasing the neurons, your calculation would be increased also, because at the end you are doing neuron calculation, you are doing the computation here, so computational cost will also increase, right? So that's why it's not a recommended way. Again, there is another issue. Let's say I'm having a sentence and which have actually the word which is not present in my corpus. Let's say I can write my name is Buppy. Let's say this sentence actually I'm having. Okay, now just try to see, these are the word is having in my entire corpus. No, these are the word is not present inside my entire corpus. Okay, that means what will happen, it would be out of vocabulary issue. That means the vocabulary you are having right now, it is not present inside your corpus, so your model won't be able to understand these are the word, because you haven't used this data during training. So whenever you are giving during testing, definitely it won't be able to understand what kinds of sentence you are giving. So again, it is called actually out of vocabulary issue, OOV. Okay, out of vocabulary issue. So if you're using one-hot encoding, so you will get this kinds of issue. Okay, out of vocabulary issue. And another issue I think you saw here, you are having lots of zeros. You are having lots of zeros. And zero is what? It's a sparsity problem. That means it's a sparse matrix you are having. Okay. And whenever you are doing the computation and whenever you are using zero, okay, to perform any kinds of operation with number, so there is no meaning, right? That's why zero is an unnecessary number here. Zero is unnecessary number here. So you are unnecessarily increasing the computation here because you can see zeros is increasing the dimension in this particular case. So let me just write some of the drawbacks of the one-hot encoding. So here I'll just write the drawbacks. So the first drawbacks, you can see the sparsity. That means here you are having lots of zeros. Then the second, you can see the no fixed sized, because anytime your sentence might be anything. Okay. Let's say here I have taken people watch DS with Bappy. I can take also my name is Bappy Ahmed and I'm a data scientist. Now just count of the sentence length. You will see that it will be bigger. Okay. So you can write no fixed size. Then the third you saw OOV, that means out of vocabulary issue. And the fourth important things, it is not capturing semantic meaning. Semantic meaning means after people watch is coming, after watch DS with Bappy is coming, before DS with Bappy watch is coming, before watch people is coming. These kinds of semantic information, semantic relationship, this is not capturing because it's just a number. And whenever this word is present, it is giving 1. Otherwise, everything it is giving as 0. That means this particular number is not capturing the semantic information of your sentence. But whenever we are using text data, so definitely it will have the semantic relationship. That means it will follow one grammar. What kinds of grammar? Let's say whenever I'm writing any kinds of sentence, let's say my name is Bappy. So my is a subject. So my is a subject, name is noun. Okay. Is verb. Bappy is also a noun. That's how it is following one grammatical rule. Okay. That means after my name will come, after name is will come, after is Bappy will come. Okay. So it is following one relationship. It is following one relationship like that, right? So this kinds of relationship, it won't be able to capture if you're using one-hot encoding. Okay. So that's why we can't use this particular method. Okay. We can't use this particular method whenever we want to convert our data to numerical representation. That means vector representation. Okay. Inside generative AI. So this technique you don't have to follow because it's like very basic technique. If you're doing any machine learning project, if you have some level of categorical data in a column, you can use this one-hot encoding there. But whenever you are working with completely textual data inside generative AI, I won't suggest don't use this particular method because I already showed you some of the drawbacks you will get here. So now the second technique we'll be discussing about bag of word. Okay, bag of word. Now let's try to see the bag of word example, like how it will work. So for this, I'm going to copy the same table. So again, you can consider the same things corpus. So I'm using the same table. That means it will have the same corpus. Again, the number of, let's say, unique word would be 5. And you have to create a 5 unique word table. So let me again copy. Now, how this bag of word will work? See, this bag of word will work based on the count. Okay, based on the count of the word present in your entire corpus. So let's say, first of all, it will see people. So now just try to tell me how many times people you can see in this particular sentence. I can see only one time. So people is coming only one time. Okay. Now the next word, watch. So how many time watch is occurring in this particular sentence? Only one. Then DS with Bappy, one time. And write is there? No. So write is not there. It would be 0. And comment is not also there. It would be 0. Okay. Then the next sentence you can see DS with Bappy, only one. DS with Bappy now occurring 2 times. So it would be 2. Then watch is occurring only one time, 1. And people is not there. Write is not there. Comment is not also there, right? Now the third sentence, people is coming one time. Write is coming one time. Okay. Comment is coming one time. And watch is not there. DS with Bappy is not there. Now the last sentence, DS with Bappy only one time. Write is only one time. Comment is only one time. DS with watch is not there. People is not there. Okay. So this is how actually you'll be generating the vector. Okay, this is how actually you'll be generating the vector. Now just try to match with your previous vector. What you have observed, you see the bag of word technique you have applied, it is having very less zeros than your one-hot encoding. Okay, that means it is slight better than your one-hot encoding. Okay, because it is working based on the counting. Okay, based on the counting. Okay, counting of the word present in the sentence. Okay, this is the idea. Now research proven, research already proven that if you want to do something called classification kinds of task, let's say sentiment analysis, okay, sentiment analysis, then let's say you are performing positive negative reviews. Okay, these kinds of tasks you can use this bag of word technique to perform the text vectorization, because this is suitable for this particular task. Because if you see any kinds of sentiment analysis problem, let's say here I'm having some sentiments, this movie is wow, or you can also write this movie is amazing, amazing performance. Okay, performance. Let's say these kinds of reviews you are having. Now if I want to find the positive, okay, positive or it's a negative, I can see the, let's say, word. So movie, amazing performance. Okay, you can see amazing, this particular positive was is occurring like multiple time. That time I can consider it's a positive review. Okay, it's a positive review. So that is why it's a frequency based actually approach. So it will always try to see the frequency count in a sentence, and based on that it will decide whether it's a let's say positive sentiment or whether it's a negative sentiments. Okay, so that is why it is recommended if you're performing any classification kinds of task inside a text, you can use this particular approach. Okay, but again, one drawbacks you will see, it is not capturing the semantic information, like after DS with Bappy, what is coming, after what DS with Bappy is coming, or let's say people, what is coming, after what DS with Bappy is coming. So this kinds of semantic information it is not able to capture. So again, it's a drawback. Okay, and some of the zeros still you can see. Okay, because again it will increase that your computational cost, because zero doesn't have any kinds of meaning if you are doing any kinds of operation, right? This is the idea. Fine. So apart from that, we are having some more technique we can follow, like we are having something called TF-IDF. So we are having TF-IDF. Then we are also having another technique called word to vec. So this one use one statistical, let's say, equation to perform let's say vectorization, and this one is the deep learning based actually vectorization technique. Okay, and from this technique actually lots of idea came how we can use the transformer model to perform the feature extraction, because whenever I'll teach you this word to vec technique, I'll show you the feature extraction technique. So how it will extract the features from a sentence, let's say from a text. Okay, so from here actually idea came, then people have actually launched transformer based actually encoding technique. That means with the help of transformer model you can perform the text representation. That means you can convert your text to vector representation, and whatever large language model you are using, okay, LLM, you'll be using this transformer based approach only to convert your data to the numerical representation. So whenever we'll do the practical, that time definitely I will show you. Okay, we'll be downloading the model from the Hugging Face. Hugging Face is also having lots of tokenizer. That means this kinds of encoding model. Okay, with the help of that we can easily convert our data to the numerical representation. Fine. So as of now, let me show you all the practical. That means that's bag of word, then TF-IDF, then what to vec. Okay, how we can use it and all. But before discussing TF-IDF and what to vec, I just wanted to show you this bag of word practical. So for this, what I will do, I will open up my Colab notebook, and there I'll show you this particular practical. So guys, here you can see I already prepared one Colab notebook for you. So one-hot encoding I'm not going to show you, because you already know how to perform one-hot encoding. So with the help of pandas library also we can perform one-hot encoding. Even we also have one, let's say, class inside sklearn library, okay, to perform the one-hot encoding. So I'm expecting if you already work with machine learning, you know how to perform one-hot encoding. And again, we are not going to use one-hot encoding technique in our analysis, but bag of word will be using sometimes, because I told you now if you are doing any kinds of sentiment analysis and all, that time you can perform, because it's easy to implement. Okay, at the end. Now see, bag of word, for this I need two library, NumPy and pandas. So let me import them. So with the help of pandas, actually I'll be creating a dataset first of all. So the same dataset example I have taken, the dataset I showed in my whiteboard. Okay, So you can see people watch DS with Buppy, DS with watch DS with Buppy. Okay, this kinds of example I have taken. Now let me prepare the data frame. Okay, so this is my data frame, and here I also have taken another, let's say, column called output. Let's say whether it's a positive, whether it's a negative. So that's how I've just given a number. Okay, it's just an assumption number as of now. Don't try to think it's an actual number. Fine. 1 means it's a positive, 0 means it's a negative. Okay, but whenever you will be using actual data, there will have the positive, negative previews. Okay, based on the text you are having. I hope it is clear. Now, if you want to perform bag of word technique, you have to use one library called sklearn. From sklearn, you have to use something called count vectorizer. Okay, so count vectorizer is nothing but it's a bag of word technique. So I know that many of you already use this count vectorizer in your machine learning, but you don't know this is a bag of word. Okay, so now just try to remember it's a bag of word technique only, right? Now we have created the counter vectorizer object. Now here I just need to fit my data, and I want to fit my data on top of my text. That means textual data. Now here I'm fitting the data. Now it will return me all the vocabulary. Now see, what will happen here? It will just assign some of the index number. Okay, it will just assign some of the index number with all the words. Now whoever having actually 0, that means this is the first index. That means this word would be considered at the very first. Then this one, that means number 1, then 2, 3, and so on, right? Now how it is generating this particular array? So let me just try to discuss. Now just try to see which word is coming at the very first based on the index comments. Now just try to see comment is there in the first sentence. No, comment is not there. That's why it is coming as 0. Got it? Now the second sentence you can see. Now the second word you can see DS with Buppy. Now tell me DS with Buppy is there? Yes. How many times? Only 1 time. That's why it's coming as 1. Okay. Then the next one, people. People is there? Yes. How many times? Only 1 time. Okay. Then the next word, watch. Watch is there? Yes, is there. How many times? Only 1 time. Then the next one, I think last one, right. Right is there? No, right is not there. That's why it is coming 0. Okay, now let's consider the second sentence. Okay, now again you have to consider based on the index. Again, comments is there? No, comment is not there, so that's why it's 0. Now next thing, DS with Buppy, yes, it is there. How many times? 2 times. That's why it's coming as 2. Okay, then you can see the next one, people. People is not there, that's why it's coming as 0. Okay, it's coming as 0, 0. Then after people, actually we are having watch. Watch is there? Yes, there. How many times? Only 1 time. Okay, then after that we are having something called this one, right. Right is there? No, right is not there, that's why it's coming as 0. That's how you have to consider for all the sentence. I hope it is clear how it is generating this particular number. Okay, and this is your vector. Okay, this vector actually you can pass to the model. Okay, this vector you can pass to the model. So if you're only printing this bow object, see what you will get. You will get one object here. Okay, you will get one sparse matrix object, and if you want to get the number, that means the complete array, you have to use this particular method called toArray. That's why every time I'm doing this one. Okay, just to show you all the number. That is the idea. Fine. Now if I want to perform on top of my new data, let's say this is one sentence I've given, Buppy watch this with Buppy. So I have to use this particular transform. Okay, transform function that time, cv.transform, pass your data and convert it to toArray again. You will see your data representation. Fine. Now what you can do, you can store your X and Y data. Let's say X is nothing but my entire bow, and Y is nothing but my output. So this is my output. Okay, positive or negative. Now you can pass this data to the model. Okay, this is the idea. Got it? Now there is another things inside bag of word called n-grams. Okay, what is n-grams? N-grams is nothing but here you see, n-grams is nothing but here you do the same thing, only you give one n-grams parameter. So let's say if n-gram parameter is 2, so what will happen? Let's say n-gram parameter is equal to 2. That means it will consider 2 word as a 1 token. Okay, 2 word as a 1 token. See, previously I took individual word, right? Now it will consider 2 word as 1 token. That means here it will come people watch. Okay, inside this box people watch will come. Then watch DS with Buppy will come. Okay, so that's how we have to take pair of word. Okay, and you have to perform the same thing. So this is called actually n-grams. Now let's say n is equal to 3. That time 3 pair will come. That means 3 word you have to consider. Okay, but I saw that people are using only 2 parameter because sometimes it is required. So let me show you one example why it is required. So let's say here I'm having a review. Movie is very good, and here I can write it, this movie is not very good. Now this one is the positive sentiment, you know, this one is the negative sentiment, you know. Okay, but how about your model? Okay, how it will identify? Because I told you based on the frequency count it can decide. Let's say you are having some word, let's say very good movie. Okay, that means it's a positive one. And if it is coming to the second sentence, let's say this is the first sentence, the second sentence, again it can consider movie very good, and it will ignore this one because it's a stop word. I think I taught you the stop word concept, right? Not would be considered as stop word. So again, your model will try to consider it's a positive. Okay, it's a positive review, but although it's a negative review. But how I can capture this negative information? So if I am doing this n grams, that means if n is equal to, let's say n gram parameter is equal to 2, it will consider 2 word as a pair. Okay, 2 word as a pair. So the first 2 word, then second 2 word, then this 2 word, and this 2 word. Okay, so it's a positive one. You can see now, you can see it's a positive one. So this movie very good. Okay, now again if I just make this sentence, let's say this word, this word, this word, this word, and this word. Now you can see easily it is capturing is not. Okay, is not. Now see, it is easily capturing this is not. That means not word as well. Okay, now easily your model can identify it's a negative. Okay, it's a negative sentiments. Okay, so that's why sometimes we have to perform this particular n grams operation. Okay, because if you're giving n gram parameter is equal to 2, that time it will consider 2 tokens. Okay, in one just let's say representation, and it can capture some of the hidden information. Okay, this is the idea. Now let's see the practical. So here you can see the same example only. You have to use the counter vectorizer. I'll convert to the text. Now see, whenever I used counter vectorizer, here I have given a parameter n grams range is equal to 2, 2, that means it will consider 2 words. Okay, now you can see people watch DS with Buppy, DS with Buppy watch. Okay, now it is considering 2 tokens. Okay, in just one representation. That is the idea. If you give 3, so if you give 3 here, it will consider as a 3 word. Okay, 3 word as a count. Okay, that's how you can consider. Fine. And if you're using 3 word, that means it would be considered as a trigram. Okay, trigram. And this if you're using 2 words, if you're using 2, it would be considered as a bigrams. Okay, this is the idea. Now there is another technique I already showed you, TF-IDF, that means term frequency inverse document frequency. So this will work based on one equation, based on one, let's say, statistical equation. So simply in Google you can search for this equation TF-IDF. So you'll see this particular formula. So yes, this is the formula, guys, it use, okay, to perform this text representation technique. Okay, so it will work based on the, let's say, weight. Let's say if anyone word is having, let's say, frequent count, okay, in a sentence, it will give more weight. Okay, it will give more weight. Now if I show you the representation, so you have to use this sklan to initialize TF-IDF vectorizer. Now inside that you can pass your data. Let's say text data I'm passing, again I'm converting to the array representation. Now see, you are getting the entire array. Okay, now see, none of the number is 0, complete 0. You will still get some number. Okay, it would be a floating number. So this technique helps us to reduce that sparse matrix dimensionality issue, because if you are using 0, okay, 0 in your, let's say, vector, you are doing unnecessary computation. That's why it will assign the weights, and weight is nothing but it's a floating number. Okay, and everywhere you will see the floating number. So this particular issue will be resolved, because still after performing bag of word you are generating some zeros. But if you're using TF-IDF, you are not generating any kinds of zeros. Okay, so this is the main benefit here, and this is better than your let's say this one bag of word. Okay, sometimes you can also use this TF-IDF technique. Again, I won't be recommended to use this one because we have some better option to do. Next thing I'll be teaching you that what to vec technique. That means we'll be using deep learning model for the feature extraction. Okay, and this will contain the semantic information, because again, if you see this TF-IDF is not able to actually contain the semantic information. That means after, let's say, people watch is coming, after watch this with Buppy is coming, this kinds of semantic information is not able to capture. Okay, so again, I won't be recommended to use this TF-IDF technique here as well. Fine. And here is the some TF-IDF value. Okay, if you are understanding this formula, you will get it. Okay, what kinds of things it is generating. But initially I won't be suggesting you to deep dive in this equation, because again it's not a recommended. We won't be using it. Okay, we'll be understanding whatever actually we need, okay, for our large language model. That's the idea. So yes, these are some actually practical I showed you for the text representation technique and word embedding technique. Now the next thing we'll be discussing about this one, word to vec technique. Okay, now let's try to see how word to vec technique works. Okay, so guys, now we'll be discussing about word to vec. So this is the deep learning approach actually. So how what2vec works and how it will extract the features from the data itself, I'll try to clarify. See, what2vec actually use two kinds of architectures. If you want to see, just write what2vec architecture. So you will see it has actually two kinds of architecture called CBOW. So here you can see, guys, it uses two kinds of architecture, CBOW and skipgram. So it's a neural network only, right? So let me show you the core mechanism of what2vec, like how it extract the features. Let's say you are having documents. Let's say you are having an entire corpus, and in the corpus, let's say you are having some unique word. So let me create a table. So I can create a table. Just a minute. So here I'll be adding all the features. And this side I'll be adding all the unique word. Let's say you are having the word of king, let's say queen, let's say man, let's say woman, and let's say monkey. So as of now, just try to consider these are the unique word you are having in that particular entire corpus. Now how your what2vec will try to extract the features. So see, it's a neural network, and neural network works based on the back propagation, because every time it will adjust the weight, based on that it will learn. And if you see the neural networks, you can't see like what kinds of feature it is extracting, because it's a completely hidden thing. If you see for the, let's say, CNN, if you see the for the NN, so these feature extraction things is a completely hidden. You don't know what kinds of feature it will extract. But as of now, let's consider it has, let's say, generated some of the features. Let's say the first features it has generated based on this word gender, because gender features can match with all the words you can see, because all the, let's say, word I'm having, let's say all the entity I'm having, it has the gender, yes or no, right? Then it has also generated another features, let's say wealth. Now you can see wealth is also matching with all the words. Now you can also consider power, then weight, then speak. See, as of now, I'm just assuming these are the features my model has generated, because here we're using deep learning model. I think I showed you. Now see, that's how actually it will identify the features. That means the vector representation. First of all, it will see king has gender or not. Yes, king has gender, and it's a male king. Let's say male king. Queen has gender. Yes, let's say 0. 0 means female. Man has gender. Yes, 1. Woman. Yes, that means 0, because man I'm considering as 1 and woman I'm considering as 0, right? Monkey has also gender. Let's say 1. Now wealth, king has wealth. Yes, king has wealth. Let's say I can assign as 1, because king is having lots of wealth. Queen is also having wealth, let's say, because queen is a part of king, right? Man is also having wealth, but less than king and queen. So I can give, let's say, 0.5, okay? Or I can give, let's say, 0.2, fine, because again, they are king and queen, right? Woman has also wealth, let's say 0.2, less than man. Monkey doesn't have any wealth, I will give 0. Now power, yes, definitely king has the power. Queen also has the power, okay? But I can just decrease a little bit. Let's say less than king, okay, I can give 0.7. Man has also power, let's say 0.3. Woman has also power, let's say 0.2. Monkey, no, monkey doesn't have any power. Now weight, yes, king has weight, let's say I will give 0.8. Let's say this king is a little bit obese. Queen, yes, she has also weight, I can give, let's say 0.5. Very slim queen. Man, let's say 0.7. Woman, let's say 0.5. Monkey, let's say 0.3. Fine. King can speak. Yes, king can speak. Queen can also speak. Man can also speak. Woman can also speak. Monkey, let's say, can't speak. Okay. Now see, beautifully, I have generated some of the vector. Okay, beautifully, I have generated some of the vector. And I haven't generated, it has generated by your what2vec algorithm. Okay, what2vec model. That means this architecture, the deep learning architecture you saw. CBOW. Okay, CBOW and skipgram. Okay, so these are the architecture. Let's say it has generated these features. Now if I tell you, just try to give me the king vector. So what it will give me? It will give me, let's say, king is equal to, let's say this is the king vector. So I can write here 1, then 1, then 1, then let's say 0.8, let's say 1. This is my king vector. You can also give me the queen vector. So here is the queen vector 0, 1, 0.7. Let me just write 0, 1, 0.7, then 0.5 and 1. Okay, this is the queen vector. You can also give me the man vector. Here's the man vector. 1, 0.3, 0.3, 0.7. 1, 0.3, 0.3, 0.7, and 1. Okay. Then woman 0, 0.2, 0.2, 0.5, 0, 0.2, 0.2, 0.5, and 1. Then let's say this is the monkey vector. 1, 0, 0, 0.2, monkey. 1, sorry, should be 1. Then 0, 0, 0.3, 0, 0, 0.3, sorry, 0.3, and I think 0. Okay, see all the vector I got. Now if you plot them in a dimensional space, let's say this is my dimension. As of now I'm just drawing 2-dimensional dimension, okay, because 3D 4D I can draw here, that's why I just consider 2-dimensional space. Now here you can let's say this is your x coordinate, this is your y coordinate. Now let's say first of all I want to, let's say, represent king here. So let's say king is here. Let's say this is the king. This is the king vector. Okay, this is the king vector. I can write this is the king. Now if you just plot the queen also, you will see that queen will come close to king. Okay, queen will come close to king. Why? Because if you see the vector, okay, if you see the vector, they are very closely related vector. You can see, let's say if you calculate the queen distance with respect to all the vector, you will see that queen will have very less distance with the king because both are similar. Okay, both are similar. Okay, because you can see queen is the part of king, so all the features are already matching with the king. That's why it is coming to close. So that means it's a cluster. Okay, it's a cluster of king and queen, so they are falling in the same cluster. Now similar wise, if you plot the man and woman vector, you will see that they will come nearly. Let's say this is your man. Okay, man vector, and let's say this is the woman vector. Because if you see carefully, man and women vector, they are closely related. Okay, they are almost similar, so that's why they are coming in the same cluster. So again, it's a cluster, okay, for man and woman. And if you see the monkey, okay, monkey is a completely different entity. You can see the vector is also different. So let's say monkey will come here. So I can take a new pen. Let's say this is the monkey. Monkey, okay, and monkey, it is present in the different cluster. Okay, so that's how it is capturing the semantic information, okay, between multiple words. Now let's say there is another sentence you are writing. Let's say I am a princess. Okay, princess. Now tell me where this princess will come, in which vector, in which space, okay, in which cluster. It will come definitely inside this particular cluster, because if you just extract the features from the princess, you will see that it would be close to king and queen. Okay, so that's how this word to vec can actually understand the semantic information of a word. Okay, so that's why it is so that's why word to vec is the much better than your previous whatever technique you have learned so far. Okay, and from here actually your actual concept starts, like whatever things you will be learning in future. Let's say transformer based encoding, like how transformer model extract the features. That's how it extract the features. Okay, because then it's a deep learning model, and by the backpropagation itself it will generate these are the features. But as a human you won't be able to see the features, but here we are assuming, let's say these are the features your model may create, and based on that, that's how it will generate the vectors embedding. Okay, and when it comes to semantic information, that's how it will let's say capture the semantic information, because it will plot all the vector in a dimensional space, and then it will try to find the relationship whether king and queen are same or not, man and woman are same or not, monkey is a different or not. Okay, I hope it is clear now. So let me show you one image actually, experiment of what to vec. You can see this is one experiment for the what to vec. So here you can see we are having three kinds of word: king, man, and woman. And whenever what to vec is applying on top of it, it is generating some features. You can see. So this color represent the features. Let's say these are the features it has generated. Let's say this is wealth, this is power, this is speed, this is, and let's say this is the weight. I can see king color is different than your man and woman. Now see, man and woman color, they're closely related. You can see all the color is matching. Okay, all the colors are matching. That's how it is making a separate cluster of man and woman, and king is a different entity here. Okay, I hope it is clear now. So now let's see the practical of what to vec, how we can use what to vec in a Python code. So for this I'm going to use one dataset. So let me show you the dataset here. So the dataset name is Games of Thorns book dataset. Okay, dataset in Kaggle. I think you know what is Games of Thorn. Okay, it's a series actually. So if you don't know, you can simply search on image. See, this is one actually series. Okay, this is a movie series actually, Games of Thorns, and it is having different characters. So if you have already watched this particular, let's say, series, you will know okay about this particular character and all. So based on this particular series, one book has been published, and this dataset is available in the Kaggle also. This book dataset. Now this book contains all the dialogue okay present in that particular series. Okay, see all the dialogue. It is having different txt file, you can see, based on the, let's say, season. Okay, it is having different dialogue from all the characters. So what I'll do, I'll just try to download one txt file, and I'll just try to apply what to wake on top of it, and I'll try to see what are the character are closely related. That means I'll see these kinds of, let's say, representation. That means whether some character are in the same cluster or not. Because if you see this series, some of the character would be closely related. Okay, let's say character 1, let's say character 2, they're similar kinds of character. So these two vector will come closely. Okay, that's how we want to see the relationship okay between the data. So I already downloaded one txt file. You can also download. Just try to search for Games of Thorn books in Kaggle. You will see this particular data. Just try to download one txt file. So let me show you the notebook. So guys, this is the notebook, and here we'll be showing you the what to fake. Now let me connect, and this dataset is already available in this link I have already given. Now let me download and let me upload in my Google Colab. So here I can upload this data. So I'll create a folder here called data, and inside that I can upload this txt file. Now first of all, let's import some library, NumPy, Pandas, and GenSim I'm importing because what to wake is there inside GenSim library. Okay, if you want to use what to wake, you have to use this particular library called GenSim. Inside that you have the what to wake architecture. Now let me import them. Now if you're using Google Colab, first of all you have to update the GenSim, because otherwise you will get some of the issue. So let me update. Okay, update is done. Now I'm importing like sentence tokenizer from the NLTK, and I'm also importing simple preprocess from the GenSim library, because before passing my data to my, let's say, what to wake model, first of all I have to apply some processing. Okay, processing means it will do some cleaning operation and all. Then you can pass the data. So let me import them. Now this code snippet will load your data from the data folder, you can see. Okay, so here I'm having test.txt, so it will load the data, and it will extract all the, let's say, word, that means all the sentence one by one, and it will perform the tokenization. Okay, it will perform the tokenization. That means every word will have the tokenizer. Okay, now if I show you the story, that means story list. Now see, you got your all the sentence. Okay, see, this is the entire sentence, and inside a sentence you have done the word level tokenization. Okay, this is the idea. Now if you check the length of the entire story, you have more than 8,000 actually, let's say, example here. So here you are having more than 8,000 sentence, that means 8,000 dialogue. Okay, now you can see the entire story. Now if you want to see the story 1, that means the first let's say dialogue, the first sentence, this is the first sentence. Okay, you can see, and again we have done the word level tokenization. Okay, individual token. Now we have to initialize the GenSim model. So that's how we can initialize the GenSim model. So let me initialize. Then if you want to let's say convert to the vector representation, just try to call this particular function build vocab. Now inside that pass your data. Then you have to train the model. So you have to give your data, total example. Then total example, you will get total example from the model.corpus count. That means it will count the entire corpus, and it will give the count, and you have to give the epoch. Okay, epoch, you can take the default actually epoch from the model itself. Now see, my training is completed. Now if I want to see the similar, so similar of Denarize. So Denarize is a character inside this particular, let's say, series. So see, she is the character. Now you can see the similar score of the Denarize with, these are the word. Okay, these are the word. But see, again, you will get some, let's say, random output, because here we are only using one dialogue. That means one txt file. I'm not using the entire txt, entire dialogue, because unless and until my model is not getting the entire dialogue, it would be a little bit difficult for it to match those character. Yes or no, right? So if you're doing it, just try to take all the data and try to perform this job. But here, just to show you, I have taken only one txt file. Now you can see with still word, it is having 0.99 okay percent relationship. Okay, linearize. Then and prince. So prince is another character. Prince in games of songs. See, with him actually, her character is matching. If you watch the series, actually, will see that with him, her character is matching. Okay, mostly. So you can see. Then deny. Then Dotarki also is a character. See, okay. So that's how we can actually match. Now see, it's not actually properly visible. So what I can do, I can also plot them in a. So what I can do, I can also plot them in a visual graph representation. I'll tell you, but before that, let me show you. If you want to, let's say, see the relationship between two characters, you can use this similarity function inside that give two characters. Let's say Arya and Sansa. So if I give Arya and Sansa, so they are having. This is the relationship. Okay. Now, if you want to get all the vectors, you can execute this code. It will give you all the vectors. Okay, all the vectors for the entire text you have given. Okay, and the shape of the vector. See, now let me show you the visualization. I will apply the PCA, that means principal component analysis, to reduce the dimension. That means I want to plot in a 3-dimensional space right now. So here I'm initializing PCA component. Now PCA.fit, I'm giving my data, that means vector. So it will give me the 3-dimensional vector right now. That means from 100 dimension, it has reduced to 3-dimensional vector. I think you know what is PCA, principal component analysis in machine learning. We can use it to reduce the dimension size. Now you can see the dimension right now. So this is the dimension 3. And here we are having 3840 example in this particular entire text. Now see, if I want to plot it, I can use plotly library. Now inside that, just pass your data and set the color. See, it will show you the entire representation of the data. See, that's how we are getting a 3D space. See, this is the 3D space. Now see the different word. Okay, different word and their similarity. So here you can see they are closely related. These are the cluster. So this word is nothing but, so this red is nothing but, just try to see, it's a take, and this blue is nothing but, it's a put. That means put and take, they are falling in the same cluster because they have the relationship. Okay, if you just find in a grammatical way, you will see that they have the relationship. And apart from that, you will also see some character. Okay, you can also match the character. You will see that they are falling in the same cluster. So you can play with this particular graph. I'll share the notebook. You can play with this particular graph. See, that's how beautifully it has stored the data in the dimensional space. Okay, and that's how your model will identify, okay, the semantic relationship, okay, between two words. That means I showed you now here the semantic information from the word itself. I hope it is clear now. Fine. So yes, so that's how actually we can use this word to vec. And if you're using word to vec, you have to pass this particular data. Sorry, after this data. Okay, the vector we are getting, the entire vector, that normalized vector. Okay, and this is your vector representation. This vector you have to pass to the model. But again, we won't be using that. We have just learned this word to vec just to understand how my transformer architecture will be working, how it will extract the features, and how it will get the, let's say, semantic information. So in transformer architecture, you use something called attention mechanism. Let's say attention model. With the help of attention model, it can actually understand the semantic information in a good way. Okay, this is a little bit advanced concept. Okay, that's the idea. So yes, this is what actually we can perform our data representation. That means text representation. And that's how we can perform the vectorization technique. So why we learn this? Because going forward, whenever we'll be learning about, let's say, large language model and all, before understanding large language model, I just wanted to let you know how data would be prepared for the model. Okay, now I think you got it, how we can prepare our data for the large language model. Okay, if I have any kinds of raw text, how we can convert to the numerical representation, and which approach would be better. Because finally we saw that this word to vec approach is better because it is able to extract the semantic information. Okay, semantic information, because it is a deep learning model. Okay, this is the idea. So yes, I hope guys you got it. Now in the next video, we'll be using all the, let's say, topic we have learned so far, let's say text preprocessing and text representation technique. And we'll be doing one small project with the help of machine learning. We'll be doing one text classification project, which as of now we have learned about text preprocessing and text representation technique, like how we can convert our textual data to numerical representation, that means the vectorization, right? So we'll be using all the concept we have learned so far, and we'll be doing one hands-on, that means we'll be doing one practical. So here we'll be implementing one text classification model. So in this video, my main objective is to show you how we can prepare your dataset for the model. That means how we can apply all the preprocessing technique, how we can apply these kinds of text vectorization techniques so that you can use those data, okay, for the model training. But model wise, actually, I'm not going to use a large language model as of now. I'm going to use simple machine learning model. Later on, I will also show you how you can use large language model. Okay, because it's the like very initial phase we are doing. As of now, we haven't learned about the LLM. That's why I'll be using simple machine learning model. So let's open up our Google Colab and let me show you the text classification practical there. So guys, as you can see here, I already prepared one notebook for you, and the dataset actually I'm going to use. So this is the link of the data. So the dataset name is IMDb movie review dataset. So this dataset is having 50k movie reviews. So you can download this data from the Kaggle. So Kaggle website, it is available. So it is having reviews based on the sentiment, whether this reviews is a positive or negative. Okay, so it's a classification problem statement. So I already downloaded the data. I have already given the link. You can download the data. So let me upload the data here. So I'll just try to upload. So this is my data. So here, let me upload it. Okay, my dataset is uploaded here. Now, the first thing what we have to do, we have to import some of the libraries. So here I've already listed down all the libraries you need for this experiment. So I need NumPy, Pandas, Matplotlib. Okay. Then I also need tensor split, counter vectorizer, TF-IDF transformer. Okay, so everything I have just imported here. And as of now, I'm not going to use this keras. So let me just remove it. It's not required. So here I already told you I'll be using simple machine learning approach. So I don't need to use any kinds of deep learning library as of now. So fine, you can see guys, I have imported all the required library I need, and definitely I will explain whenever I will use it. I'll tell you, okay, why we're using this particular library. Now let me import all of them. I think NumPy and Pandas we already imported here, so I don't need it. I can delete it. Now you don't need to execute this line because here I have my data in my Google Colab. You can see Google Colab space. But if you have your data in your Google Drive, that case, what you can do, you can mount your Google Drive. So I'm not going to execute this line. So directly I'm going to assign my data path. So I'll copy, and here I'm going to mention the path of my data. Okay, so let's say this is my data path. Now I'll execute. Now I will load the data with the help of Pandas library. Now see guys, this is the entire data you are having, and here you are having the this one, your reviews as well as the sentiment of that reviews. Now if you want to see the shape, so here you are having 50,000 movie reviews and 2 columns. Reviews and sentiment. Now see here, I don't want to take all the data because again, if I'm taking all the data, it will take lots of time to process. So I'll only take the 10,000 example, okay, from this 15,000 example. So here you can see I'm taking only 10,000 example, first 10,000. And now you can see this is my data. Now if I show you the data shape, now see only 10,000 example I have taken. Now if you want to see any kinds of reviews, you can also check. This is the first reviews. Now, if you want to see the sentiment value count, that means how many sentiment it is having. It is having 2 sentiment, positive and negative. You can see. So positive sentiment is having around 5,000, and negative sentiment is having around. It is also more of around 5,000. You can see 4,972. That means it's a balanced data. Okay, we don't have any issue with the data. Now let's see whether it is having any missing value or not. For this, I can use isNull function. Now see, there is no missing value. Now let's see any duplicates is there or not. So you can see we are having 17 duplicates. What I can do, I can drop the duplicates. For this, you can execute this line of code, drop duplicates, and in place is equal to true. That means you want to permanently delete the duplicate. Now if I execute, now see, there is no duplicate data in my dataset right now. Now let's perform some basic pre-processing. So as I already told you, inside basic pre-processing, you can perform HTML, tags removal, then lowercase operation, stop word remover. So these are the things you can perform. Now see, from my previous notebook, that text pre-processing notebook, I have taken the same function, that removes tag function. That means it will remove all kinds of HTML tags from the data, because if I show you the data, it is having lots of HTML tags because it's a extracted data from the website, right? So let's apply this function. I will apply on top of the reviews. So it will remove all the, let's say, HTML tags. Now see, this is the clean data I'm having. Now see, there is no HTML tags present inside this data. Now the next pre-processing technique will be performing the lowercasing operation. So let's perform it. So here you can see I'm applying lowercasing. Now if I show you, see all of my word has become lowercase right now. Fine. Now what we'll be doing, we'll be removing the stop words, because as I already told you, some stop word doesn't have any kinds of meaning in a reviews whenever you are performing any kind of sentiment analysis, because it will see the positive and negative words, okay, to differentiate whether this sentiment is a positive or negative. So here you can see here I have written a lambda function, so it is doing the same thing. You can also use the previous function I showed you in that notebook. Either you can also follow this particular approach. Okay, so here I'm using lambda function, and lambda is a one line function. Okay, in the one line I'm taking all the word one by one, and if any stop words is there, okay, I'm just trying to remove that stop word with the empty space. That is the idea. Now let me execute. Now see, there is no stop word present in this data right now. Fine. Now let me show you my head of the data. Now what I have to do, I have to just separate out my x data and y data. That means my independent variable and dependent variable. So independent variable means this is the review one, and dependent variable means this is the sentiment. That means this sentiment is my level right now. So I'll store inside x, and level I will store inside y. Now this is my x. That means the entire review, and this is my y. That means my sentiment. Now one issue you can see, sentiment is nothing but it's a text. Okay, it's a text. You can see it's a string, but what I have to do, I have to convert to the numerical representation. So here I can simply apply label encoder. So it will assign positive with 1 and negative with 0. So let me apply. So for this I'm using label encoder from sklearn, initializing the object, and I'm feeding my y data. Now see, your data will become 0 and 1. Okay, that means it has converted to the numerical representation. Then what I have to do, I have to perform the 10 test split, because I have to keep my data for my training as well as the testing. And the test size is I have given 0.2. That means 20% data I'm keeping for the testing and 80% data I'm keeping for the training. So let me perform. Now this is the training size and this is the testing size. Fine. Now I'll be applying first of all bag of word. Okay, I already taught you the bag of word. I think you remember. So I can use the counter vectorizer for this. Now I have to apply the bag of word on top of my reviews. Okay, reviews is my like input data, right? Then I'm also performing on top of my test data, because I'm having two kinds of data, training data as well as the testing data. And I think you know, whenever you are performing on top of training data, you have to use feed transform, and whenever you are performing on top of a testing data, you have to only use transform, okay, math function for this. Then I'm converting to the array representation. Now this is my training vector, and if you want to also see the testing vector, this is your testing vector. Okay, now here we'll be using one machine learning model called naive Bayes. Inside naive Bayes, we're having one naive Bayes version called Gaussian NB. Okay, Gaussian naive Bayes, will be using this particular algorithm. So here you can see I'm feeding my data, so x train and y train. Now let me train my data. So here I'm only showing you how we can preprocess your data, how we can prepare your data for the model training and all. But going forward, here we'll be using actually transformer based architecture. Okay, that means large language model we'll be using here. Now this is the training I have done. Now we'll be doing the prediction on top of my test data. Then we'll be calculating the accuracy score. Okay, now let me execute. See, this is the accuracy score I'm getting if I'm using Gaussian NB, and if I'm using bag of word, okay, bag of word technique. So I'm getting 63% accuracy. Now you can see this is the confusion matrix. Now if I'm applying random forest classifier on top of it, so now let's see the accuracy I got. So guys, you can see after applying random forest classifier and I was using bag of word, I'm getting this accuracy, 84% accuracy. Now see, we'll be using bag of word only. Now instead of taking all the features, what I will do, I'll take maximum features 3000. Okay, now you can ask me what is maximum feature 3000. I think you saw the entire corpus, right? I already told you the corpus. Okay, about the corpus. Corpus means the entire data, and from the entire data I'm only considering 3000 unique word. Okay, 3000 unique word, 3000 frequent unique word. Okay, this is called maximum features, because see, I don't need all the features, because if I'm using all the features, my dimension will increase, right? And I don't need to increase my dimension. Okay, if my dimension is increasing, that means my model will get more complexity, right, to perform the prediction on top of it. And here I'm using a machine learning model. Okay, I think you can see. So that's why I'm taking most frequent 3000 maximum features instead of taking all the features, right? Now it will create 3000 dimensional space, okay, 3000 dimensional space instead of taking all the unique word, right? Now see, again, I'm performing the bag of word operation. Now again, I'm taking random forest classifier and I'm training and checking the accuracy. Now if I execute, so you can see this is the result, but this result is not good enough. So we are getting closely related accuracy only if I'm using all the, let's say, features, and if I'm taking 3000 features, the accuracy I'm getting, it is almost same. Now let's try with n-grams, because I already told you about n-grams, right? What is n-grams exactly? So here, let me pass the range of 2 to, because I want to consider a pair, okay, pair of word. That's why I have given 2 to. That means it will consider 2 word, okay, as a one pair. That's the idea. And here I'm only taking 5000 most frequent word, okay. Now again, I'm performing bag of word operation, then random forest classifier, then I'm calculating the accuracy. Now let me show you. So guys, you can see this is the result actually I'm getting. So now in the summary, you can see your like bag of word is working fine instead of taking the n-grams. So in some case, actually bag of word will work fine. In some case, n-grams will work fine. It's completely experimental things, okay, you have to perform. Now let's try with TF-IDF, okay, TF-IDF technique. So here is the TF-IDF code, I think you remember. So first of all, we have to initialize the TF-IDF. Then I will apply on top of my data, okay, training data as well as the testing data. So it will give me the vector. And again, I'll be using random forest classifier to train the model, and I will show you the accuracy score. Now see if I show you the accuracy. So here we are using machine learning model. That's why performance is not good. But if you're using any kinds of deep learning model, you will see that your model will perform good. Now here you can see this is the performance of the, now you can see this is the accuracy I got. So here I showed you almost all the vectorization technique we have learned. But one thing I want you to explore this what to wake one. So I already shared you the code of the what to wake. So what you have to do, just try to apply what to wake, get the vector, and try to train with random forest model, and just observe the accuracy. Okay, so this should be your task, guys, from my side, because unless and until you are not doing anything, things would be much difficult for you to learn, right? But if you are practicing by yourself, I think this will help you a lot to learn any kinds of topic. So yes, this is how actually we can perform the text classification with the help of machine learning. And that's how actually we can perform the data cleaning task, like data preprocessing and text representation. Okay, everything we can perform like that. But again, I'm telling you guys, this is not an actual way we create our application. This is just a basic introduction I have given, like how we can like do the data preparation. Okay, this is my main objective. Now in the next video, we'll be learning about large language model, like what exactly this large language model and how this large language model got trained. Okay, everything we'll be trying to discuss. So as of now, we have seen so many things, like we saw the entire generative AI pipeline, we saw the text preprocessing as well as the data representation. And I also did one practical. I just implemented one text classification with the help of machine learning model. But I already told you, see, it was just experiment, but going forward, actually, we have to use something called large language model, because here we are learning generative AI. And inside generative AI, the core component is the large language model. Now let's try to understand what exactly the large language model is and what is the core architecture behind this large language model. So guys, as you can see, a large language model is a trained deep learning model that understand and generate text in a human-like fashion. Okay. LLMs are good at understanding and generating the human language. As I already told you, inside generative AI, we're having large language model. We also call it as a generative model. And what is the use of generative model? Generative model can generate a new data. Okay, so that is why here I have mentioned a large language model is a trained deep learning models that understand and generate text like a human fashion. That means whatever model you used previously, let's say whatever traditional model you used, let's say machine learning model, it can be any kinds of traditional deep learning model. Those are the model can't generate the text like a human fashion. Okay, it can only do the prediction, because I told you the difference between descriptive model as well as the generative model. But here, this large language model can generate a text, okay, and it would be human fashion. That means the way human generate any kinds of text. Let's say currently I'm speaking, right? I'm giving you the understanding. So the same concept can be applied in the large language model also. So large language model can also mimic the human behavior. Okay, this is the main idea here. And LLMs are good at understanding and generating the human language, as I already told you. And how this LLM works? See, the core working mechanism inside LLM, it will generate the next word. So here I've given an example. Let's say the garden was full of the beautiful. Now see, this particular sentence you are giving to the large language model, okay, and large language model is able to generate flowers. That means it is trying to generate, okay, next word always, okay, it is trying to generate next word. That is the main core idea inside large language model. That means whatever, let's say, prompt we are giving, okay, whatever prompt we are giving, whatever, let's say, text it is generating, it will try to generate the next word always. Okay, this is the main logic behind the large language model. So here are some more examples. You can see it's raining cats, and so this is my, let's say, input to the large language model. Large language model will try to actually generate this particular word called dogs. Okay, now there is another one. I have 2 apples and I ate one. I'm left with. So this is the input you are passing to the large language model. So palm means nothing but it's a large language model, and it is able to predict 1. Okay, that means it is able to generate the next word of the prompt you have given. Okay, this is the main working mechanism of a large language model. Apart from that, there are some more advanced technique it usually used. I will also explain. So I will also explain like how ChatGPT was trained and how it is working and all. Okay, I think this concept will be more clear. As of now, this is the high level understanding I'm giving you how this model is working. Okay, let's say whenever it is generating something new data, how it is working. This is the main idea here. Now let's try to understand why we call it as a large language model. Because you can see, because of the size and complexity of the neural network, as well as the size of the dataset that it was trained on. That means if you see any kinds of large language model, okay, over the internet, any kinds of LLM model, you will see it is using very big and complex neural network. Okay, very big and complex neural network. Even it is trained with massive amount of data. Okay, and the model actually we are using, it is called actually pre-trained model. That means this model is already trained with massive amount of data. Okay, it is called pre-trained model, and we call it as a transfer learning. I think you have already learned transfer learning in your previous days, right? In deep learning, computer vision, machine learning. So what is transfer learning? Transfer learning means we are using an existing model. Okay, that model is already trained with some kinds of data set. Okay, this is called actually transfer learning. So here, so this transfer learning makes this generative AI so powerful because they are training these kinds of complex neural network with the massive amount of data set. So as you can see, researchers started to make this model large and trained on huge data sets, that they started showing impressive results like understanding the complex natural language and generating language more eloquently than ever. Okay, this is the main idea. That's why we call it as a large language model. Now you can see the large language model core architecture. Now many people has this kinds of question. What is the architecture actually LLM is using? Okay, see, this is the core architecture all kinds of LLM are using. A large language models are based on the transformer, a type of neural network architecture invented by Google. Those who have already learned about natural language processing, right? Those who have already learned about attention mechanism, transformer. See, you are already familiar with this architecture, yes or no, right? So you are already familiar with this architecture, and this architecture is known as transformer architecture. Okay, and it is invented by Google. Okay, and this was the main breakthrough in the field of natural language processing, even in the field of generative AI, because based on this particular architecture, all kinds of large language model you can see over the market. Okay, everything has been developed. Fine. So this is the main architecture here. So it is having two kinds of part. One is the encoder part, and another is like decoder part. And inside that you are having something called multi-head attention. Okay, no need to worry. I will explain this particular concept. I will create a dedicated video for this. How this transformer architecture is working inside our transformer architecture, what are the component it is having. Okay, everything I'll try to clarify. Okay, for this I'll keep a dedicated video. Okay, so that you can understand this transformer in depth. Fine. As of now, just try to consider this is the core architecture behind all kinds of large language model. Okay, and it is invented by Google, and this is known as transformer architecture, and it is having two layers called your encoder layer, and this like decoder layer. So this one left side, this is called encoder layer, and right side this is called decoder layer. Okay, inside that you can see different component like input encoding, multi-head attention, add normalization, feed forward. Okay, that's how you are having different component inside that. I hope it is clear. Fine. Now on top of this architecture, what they did actually, they added some more layer, they added some more functionality, and they brought this kinds of large language model, different large language model. Now let's try to see some large language model, but before that, first of all, let me tell you what makes large language model so powerful. Because I already told you, in case of LLM, one model can be used for whole variety of tasks. Like you can perform text generation, chatbot, summarization, translation, code generation, and so on. With one model, you can perform all kinds of tasks. But whenever we used to use our traditional NLP model, that means only the language model, we can only perform one specific task. Let's say you want to do language translation. For this, you have to only use language translation model, and that model can't do the code generation. Okay, but here in the large language model, you can do whole variety of tasks. I think you saw the ChatGPT. Let me show you one example. So guys, this is our ChatGPT. Now inside that, I can give any kinds of input. Let's say I'll give me the German translation of this text. Now here you can pass the text. Let's say, how are you? Fine. Now see, if I give this prompt, see, it will give me the translation in German of this text. Okay, now see, this is the translation in German. Now I can also do the sentiment analysis. So here I can write, give me the, let's say, sentiment, okay, of this text. See, it's a neutral sentiment. Now you can also perform something called language detection. So I'll give me the language, or I can write detect the language. Okay, detect the language of this text. Now see, it should give me English. Fine. So that's how, with the help of one model, you can do variety of tasks. You can also generate the code. So I'll give me a Python code for adding two numbers. See, it can also generate the codes. So this is how actually large language model works. Okay, and that makes LLM so powerful. Now let's try to see some of the large language models are available over the internet. See, I've just listed down some of them, but you will see thousands of models are available. I will also tell you where you will get all the model list and all. Okay, so as of now, just try to see, guys. We are having different large language model like Gemini. So I think you know Gemini, right? Gemini was developed by Google. Even we are having also one application of the Gemini. Let me show you. So in Google, if you search for gemini.google.com, so you'll see this kinds of application, and this is the same kinds of application like your ChatGPT. Okay, here also you can give the prompt, and here also you can get the response. Let's say the previous prompt I have given here, I can also pass it here. Okay, and in the backend they're using something called Gemini model. Okay, Gemini large language model. Then we are having something called GPT. Okay, GPT stands for Generative Pre-train Transformer. Okay, the model was developed by OpenAI. That means the ChatGPT you are using, it is using something called GPT based model. Okay, we are having GPT-3, 4. Okay, these are the model we are having. Even recently, actually, GPT published one amazing model. I think GPT 4o model. Okay, with that you can also generate videos. You can also generate like so many things. Okay, if you just search on Google, you will see different version of the GPT even there. Application and all, like, okay, everything you can see there. Then we're having something called XLM, that means cross-lingual language model. Okay, so this is one of the large language model. It is also available. Now we're having something called Llama. Okay, and it was developed by Meta AI. So Llama is having different variant like Llama 2, Llama 3. Okay, recently Llama 3 was published, 3.1 is published, I think. And this model is amazing. It can also, let's say, generate text like a human. Even going forward, we'll be also learning how we can use Llama 2, 3 model, okay, in our application. With the help of that, we'll be building different applications. Now you can see there is another model called Megatron. So Megatron is a large language model, and it's like very powerful transformer model, okay, developed by NVIDIA research team. I think you know NVIDIA. So we are using NVIDIA GPUs in our system, right? So NVIDIA team has developed this particular Megatron model, and this is one of the large language model. Now we're having something called M2M. 100. So this is called actually multilingual encoder and decoder sequence to sequence model. Okay, and it was developed by Facebook. So these are the models actually we are having. Apart from that, I told you now we are having thousands of models. Let me show you. So this is the GitHub, guys. So the GitHub name is Open LLMs. Okay, now what this guy did, actually, this guy actually listed all the large language models are available over the internet. Okay, now see, he has created one beautiful GitHub repository, and in the README file he listed down all the large language model as well as their checkpoints. Let's say you want to download this model, you can also download this model from this particular link. If you want to read the papers and blog of this particular model, he has also given the link. Apart from that, the parameter size, context length, and as well as the license. So every information you will get of any kinds of large language model. Now see, T5 is one of the large language model, then RWKV4, okay, then GPT Neo X, then YAML, UL2, Bloom, Chat GLM. Okay, now see different large language model you are having. See, okay, Falcon is also there. Then Llama 2, I already told you. Then Mistral is also there. Okay, see different large language model, and it is having so many large language model, guys. So many large language model. If you want to export, open this particular link. Just write Open LLMs inside Google. You will be able to see these kinds of GitHub. Okay, and you can also keep this link with you so that if you need any model later on, if you want to develop any kinds of projects with the help of any kinds of large language model, you can use this repository later on so that you can see the paper blog link. Okay, it will help you to understand this particular model. So guys, as I already told you, all the large language model using one core architecture, which is nothing but transformer architecture. And inside transformer architecture, I showed you there are two kinds of layer called encoding layer and decoder layer. Okay, now see, here is the transformer architecture, let's say, and it is having two kinds of part like encoder and decoder. Now I think I showed you different large language model, like thousands of large language model. Now see, all the models are not using both layer, that means encoder and decoder layer. Some of the models are using encoder layer, some of the models are using a decoder layer. Okay, and some of the models are using both layer, that means encoder and decoder both. Now here I've listed down some of the models, so this will give you the idea of what kinds of models are using encoder layer only, what kinds of models are using decoder layer only, and what kinds of models are using both layer. Okay, you can see encoder based architecture. These are the encoder based architecture like DistillBart, BART, Robata, okay, XLM, then Albart, Electra, okay, then DBARTA. So these are the model based on the encoder layer only. Okay, now you can see the decoder layer model. So GPT, GPT-2, GPT-3, okay, whatever GPT series you are having, it is using something called decoder layer only. Okay, decoder architecture only. Fine. Then both actually layer, that means encoder and decoder both layer. So we are having something called T5 BART. Then we are having something called see, this is BART actually, B-A-R-T, not B-E-R-T. Okay, this is another model. Now M2M100 and Big BART. So these are the models are using encoder and decoder. See, it's not possible to list down all the models here. That's why I just listed down some of them. But there are so many models that are using like both architecture. There are so many models that are using only encoder architecture. There are so many models that are using decoder architecture. Okay, and this is called actually transformer T. Okay, this is called actually transformer T. So by referring this particular T, you can easily understand what kinds of models are using which kinds of architecture. Okay, this is the main idea here. Now let's try to see some OpenAI based large language model because going forward we'll be using something called OpenAI platform. Okay, we'll be generating OpenAI key and we'll be implementing different projects. Now see, inside OpenAI we're having different models like GPT-4, then GPT-3.5, GPT based, DALL-E, Whishper, embeddings model, even moderation model, GPT-3 legacy model. So these are the models that are available in the OpenAI platform. Apart from that, I think recently they have released more model because it's a continuous research field. It's not like that it will be like fixed research. Every day they are bringing new technology in their platform. Okay, so if you want to learn all of them, you have to keep updated with their technology always. For this, what you can do, you can refer their website. Okay, you can refer their website and try to see what are the models they are bringing. Okay, so like that actually you will be learning a lot. It's not like that you only need to rely on your mentor. Okay, as a mentor I can give you the entire path how you can get started with. I will teach you how you can use them, but as a learner, what you have to do, you have to explore by yourself. Unless and until you are not exploring by yourself, it would be very much difficult for you, okay, to learn any kinds of topic. So that should be my suggestion. Please try to explore from your end. After this actually video, what you can do, you can search OpenAI, you can search different open source website, and you can see what are the models are came actually recently. Okay, that's how actually you can learn. And you can also create a GitHub repository like that, and you can list down all the models, okay, you will be exporting, okay, in future. That is the idea. Now let's try to see some other open source large language model. See, there are two kinds of large language models are available. One is like commercial model. Commercial model means this is the commercial model, like OpenAI based model. So if you want to use these are the model, you have to pay. Okay, you have to pay. You have to take the subscription. Okay, but if you're not interested in paying, what you can do, you can use open source large language model. So these are the models are available in the Hugging Face platform. So if you're using these are the model, you don't need to pay. Okay, freely you can access, but there you will get some difficulty because these are the model you have to download manually in your system. You have to set up everything. Okay, let's say you want to fine tune this Mistral. What you have to do, you have to download the Mistral model in your system. Now just try to see what is the size of the Mistral model. Okay, more than 30 to 40 GB. Okay, so you should have good actually resources in your system. Let's say you should have good CPU, good GPU, good memory. Otherwise, you can ever train this particular model. But if you're using commercial model, okay, let's say you are using OpenAI model. Okay, that time what you can do, you can use their platform, like OpenAI platform, to fine tune these are the model. Okay, you don't need to download these are the model in your system. So going forward, I will teach you how you can use a commercial model as well as the open source model both. Then you can decide which one you will be using. Okay, it's up to you. Now these are some open source large language model like Mistral, Llama, Gemini, Falcon, okay, Cloudy, then MPT 30B and StableM. Okay, these are the models actually we are having as an open source model. Apart from that, there are so many model. I will tell you, there is a platform called Hugging Face. Inside Hugging Face, you will see all kinds of large language models are available there. Fine. What can LLM be used for? I already told you, you can use large language model for the text classification, for the text generation, for text summarization, conversation like chatbot, question answering, speech recognition, speech identification, spelling correction, and so on. That means whatever task you can see in the field of natural language processing, okay, all kinds of tasks you can perform with the help of large language model. Only one model. I think I showed you one example of the ChatGPT. Now there is another concept you will be getting inside large language model, which is nothing but prompt engineering and prompt designing. Now you can ask me what is prompt engineering and prompt designing. So you can see all the text that we feed into an LLM as an input, it is called actually prompt. And this whole art is known as prompt designing or prompt engineering, which is about figuring out how to write and format prompt text to get LLMs to do what you want to do. Okay, that means whatever input you will be passing inside large language model, okay, this is called actually prompt. And the way actually you will be giving the prompt, the way actually you will be preparing the prompt, this is called prompt designing or prompt engineering. Okay, now let's say here two example I have kept. It's raining cats and, okay, let's say this is your prompt. You are giving this particular input to the large language model, and your large language model will try to predict dog. I think I showed you, okay, that text word generation. Okay, next word generation. Then I have another example. I have 2 apples and I ate one. I left with, this is the input. Now your model will try to generate 1. Okay, now apart from that, we are having some types of prompt like few shot prompt, 0 shot prompt. Okay, these are the types of prompts are available. Let me show you. So this is called actually 0 shot learning, 0 shot prompting. That means here you are only giving the, you can see the approach using a single command to get an LLM to take on a behavior. It is called actually 0 shot learning. That means you are only giving a input, and your large language model will give you the output. Let's say this is your prompt: write me a poem about Ada Lovelace in the style of Shakespeare. Okay, this is the input. Now there is another one: explain the quantum physics to me like I am 5 years old. Now you are giving this prompt to the large language model, and large language model is generating the response for you, the answer for you. Okay, this is called actually 0 shot learning. Okay, 0 shot learning. Now there is another learning called few shot learning. In few shot learning, in addition to just providing an instruction, it can be helpful to show the model what you want by adding the example. It is called actually few shot learning. So in few shot learning, what you will do, you will give some example. Okay, the prompt actually you are giving. Let's say here you are giving a prompt: convert the text from English to French. So with this prompt, you will pass some example like English to French example. Let me show you. So let's say this is the few shot from example. Let's say this is the prompt you are giving: convert the text from English to French. Now you are giving English as well as the French, English as well as the French. Okay, that means you are passing some example. Okay, instruction as well as the example, and your model will try to give you the response. Okay, after that, that means you are teaching your model how you're expecting the results. Okay, this is how actually you can pass the few shot learning or few shot prompting inside large language model. Okay, so going forward, we'll be also learning this thing: how we can add our system prompt, how we can add the user prompt. Okay, how we can give few shot actually prompting, how we can give, let's say, 0 shot prompting. We'll be learning whenever we'll be using large language model. And always try to remember, if you want to get a good response from the large language model, you have to go with the prompt engineering and prompt designing. This is the main idea here. So yes guys, this is all about our large language model, okay, which is LLMs. So I hope you got the clear-cut understanding about large language model, what exactly large language model is, and what is the core architecture it is using in the backend. So in the next video, I'll try to explain that core architecture, the transformer architecture, how transformer architecture works, and what are the components are available inside transformer architecture. So here we'll be discussing one amazing research paper called Attention is All You Need. So this research paper published by Google, and Google actually brought this particular research called transformer. So here is the research paper, guys. Attention is all you need. If you are interested, read this particular paper. What you can do, simply search by this name. You will get this research paper. You can see this is from Google Brain. Okay. And you can see this is the architecture, transformer architecture. But I know that first time it would be a little bit difficult for you. understanding this architecture from this particular paper. So what I will do, I'll just try to break down this actually architecture, and I will discuss each and everything, all the components, like what is input encoding, like what is multi-head attention, what is add normalization. Okay, everything I'll try to discuss. Okay, then this part would be more clear. Then once we got the understanding, then if you come to this paper, this would be very much easy for you to understand this architecture. Okay, like how they have let's say created this architecture. And if you're interested in learning the mathematics behind it, you can go through this paper. Okay, if you want to deep dive into this, you can go through the paper. It will give you the comprehensive idea. Now to explain this actually transformer, let's say concept, I'm going to refer one amazing blog by J. Llama. Okay, so this is one of the amazing guy, and he has created so many content related actually NLP. So this is one of the best resources you will find over the internet if you want to understand the transformer architecture. So this guy actually used so many visualizations, so many images to explain this architecture. Okay, so we'll be referring this blog to understand the entire architecture. I could have written everything on my blackboard, but I thought if I show you the visualization, it would be more, let's say, good than the writing on my blackboard, right? So if you want to understand this transformer architecture, so what I feel like this is going to be one best resources for you, because it is having so many visualization. Okay, we can easily understand what is happening inside transformer architecture. So now guys, let's try to understand this architecture. Now let's say this is your transformer architecture. As of now, just try to consider this is a black box. Okay, it's a transformer architecture and you don't know what are the component it is having. So here you are giving one input data. Okay, and here you are getting one output data. That means you are performing language translation operation. So here you are passing this French input and you are getting English output. Okay, this is the idea. Now let's try to see what inside this particular transformer. Okay, transformer block. Now see, inside transformer block you are having two kinds of layer. One is the encoder layer and another is the decoder layer. As I already told you, transformer architecture is having two kinds of layer. One is encoder layer, another one is decoder layer. Now you are passing the input. Okay, you are passing the input to the encoder layer. See, this French input you are passing to the encoder layer, and the output you are getting, that English translation you'll be getting from the decoder layer. Okay, this is the main idea. Now let's try to break this encoder and let's see what are the component we are having inside encoder layer. Now see, if I show you this entire architecture, okay, in a low level, now you can see inside encoder we are having some more encoder layer. Okay, we are having some more encoder layer. How many encoder layer? You can see 1, 2, 3, 4, 5, 6. That means 6 encoder layer we are having. And how many decoder layer we are having? Again, we are having 6 decoder layer. That means the architecture you can see here. Okay, the box you can see here, encoder box and decoder box. Inside that you are using 6, okay, 6 stack of encoder and 6 stack of decoder layer. Okay, and inside that your input is going and it is processing this input and you are getting the output. Okay, this is the, so that's how this architecture consists of. Okay, I hope it is clear. Now let's try to see what we are having inside the encoder layer. Okay, now if I show you the encoder layer, see, inside encoder layer we are having two kinds of layer. One is like self attention, other is like feed-forward neural network. And what is feed-forward neural network? I think you know, that means the artificial neural network. Okay, if you're already familiar with ANN, you know what is feed-forward neural network. Okay, it's a artificial neural network at the end. Now let's try to understand the self-attention, because I know that many people will have the confusion what is self-attention here. Okay, now let's see. Now you can see this is the encoder. Inside encoder we are having self-attention as well as the feed-forward, and inside decoder also we are having self-attention, and another actually additional layer we are having which is called encoder and decoder attention, and the last layer you are having which is nothing but feed-forward neural network. So this part we'll be discussing later on. As of now, let's try to discuss this encoder layer and this self-attention part. Okay, now let's say you are passing the French input. You can see this is your French input. I don't know how to spell them, but just try to consider this is your French input. So the first thing what you have to do, the first thing you have to perform the text preprocessing, then text representation, yes or no. So here first of all you have to convert your textual data to the vector representation. Okay, so based on the paper they are using something called what-to-vec technique to perform the text representation technique. That means they are converting their text to vectors with the help of what-to-vec technique. And what is the dimension? Okay, what is the dimension of the vector? They are getting 512 dimension. Okay, 512 dimension for the each of the vector. Okay, this is the idea. Now let's say they have converted to the vector representation. Now what they are doing, they are passing this particular input to the self-attention layer. You can see they are passing the input to the self-attention layer. Self-attention layer is giving one output, which is nothing but Z1, Z2, and Z3. And this Z1, Z2, and Z3 will pass to the feed-forward neural network. Okay. Now let's try to understand how it is encoding. Okay, how it is encoding this particular input. Now see, to simplify this particular understanding, what JLMR is doing, he is using two words actually, which is nothing but thinking and machines. Okay, let's say you are having two words, thinking and machine. First of all, what you have to do, you have to convert this text to vector representation with the help of word2vec. And what dimensional vector you will be getting? 512. I think I showed you here. 512 dimensional vector it will return. And this vector will be passing to the self-attention layer. Self-attention layer will give you Z1 and Z2. Then it will be passing to the feed-forward neural network. Again, feed-forward neural network will give you some of the output. And that output again you will pass to the encoded 2 layer. That means I showed you now. We are having stack of the encoder layer here. See, stack. That means after getting one output from one encoder layer, it will go to the another encoder layer. Then again, it will pass to the another, then another, then another. That's how we have to. That's how actually it will pass through 6 encoder layer. Okay, so that is what actually he is explaining here. You can see. So here you can see after one encoding, it is passing to the second encoding layer. Okay, this is the idea. Now let's try to understand what we are having inside self-attention. Now see, self-attention at high level. Let's say here we are having a sentence. The animal didn't cross the street because it was too tired. Now here just try to understand. The animal didn't cross the street because it was too tired. Okay, it was too tired. Now, who was too tired here? Okay, definitely the animal was too tired. Yes or no? So as a human, actually, we can understand it means this is the animal. It is indicating the animal. But what about the machine? How machine will identify whether this animal is the it or not? Okay. So for this, it use something called self-attention. Okay, self-attention mechanism. Now let's try to understand how it will use that particular concept. But before understanding self-attention, just try to see how it will give the self-attention to the word. Let's say here you are having the input. So this is the input. The animal didn't cross the street because it was too tired. Okay. Now whenever I'm referring this it, now here what it represents? Definitely it represents the animal. Okay. You can see this darker color. That means it is more focusing on the animal part. Okay. The animal part, because the animal is nothing but it. Okay. That means your machine will try to understand. Okay. If I want to consider it, I have to give the weightage to the animal didn't. Okay. These are the actually what. Okay, even 2 also. Okay, 2 tried also. These are the what it has to give the attention. Okay, unless and until it is not giving the attention to this word, how it will identify whether this 8 is represents the animal or not. Okay. Now you can ask me how it is identifying whether it has to give the more weightage to these words or not. Okay. So for this, we'll be understanding the self-attention in detail. So here you can see he has given one example. Let's say this is your input. Input means your 2 words, thinking and machine. So the first thing what you have to do, you have to convert them to the embedding representation. That means the vector representation. Then what will happen? Your transformer will generate actually 3 weights. Okay, you can see it will generate 3 weights: W, okay, WQ, WK, and WV. And how weight initialization happens, I think you know. Okay, there are different techniques for the weight initialization, and these weights would be updated during back propagation. Okay, BP. I think you already know about artificial neural network. Okay, how it got trained usually, right? How it do the back propagation and all. This like very basic concept I'm expecting you are familiar with already, right? So these are the weight would be initialized at the very first, and this weight should be updated during back propagation technique. Okay. Now you can see it is generating some more actually vector. The first vector it is generating queries, keys, and values. Okay. Now you can ask me how it is generating these are the values. See, first of all, what it will do, it will take this particular x1. Okay, it will take this particular x1 and it will multiply with the WQ. Okay, it will multiply with the WQ. So it will return you Q1. Okay, then it will take the x2. It will multiply with the WQ. It will return Q2. Okay, so that's how actually we'll be getting something called query vector. Okay, query vector. Then again, it will multiply x1 with WK. Okay, and it will return you K1. Then it will multiply x2 with WK, it will return you K2. So here you will be getting keys vector. Okay. Then you will be multiplying this x1 with WV and it will return you V1. Then x2 with WV, it will return you V2. Okay. So that's how you'll be getting values vector. Okay. So that's how this 3 vector would be generated: queries, keys, and values. Okay. I hope it is clear now. Okay. Now let me clear all the line here. Yeah. Now let's see the next actually mechanism. See, I think you got it. That means we are having our input data. That means input word, thinking and machine. And first of all, we have to generate the embeddings. Then after that, with the help of x1 and x2, that means this vector, we are generating queries, keys, and values. Okay. And how? I think you got it. The multiplication actually strategy. Now, the thing is like, it will generate one score. Okay. How it will generate the score? See, to generate this code, it will use this q1. Okay. Q1 vector, and it will multiply with the k1. Okay. That means q1 will multiply with the k1. Okay. This vector, that means keys vector. Query will multiply with the keys. Okay. And you will get one score. Let's say as of now, this is the assumption score he has given here, 112. Fine. Then for the next word, you can see it will multiply q1 with k2. Okay. Q1 with k2. And here the score, let's say 96. Okay. Now from this score, you can see it is giving more score to the thinking word. Okay. To the thinking word than the machine word. Okay. That means it will more refer this thinking word. It will more give the attention to the thinking word. Okay. And that's how actually it is calculating this particular score. I think you saw this graph now. So how it is giving the attention to the word. Okay. That's how actually it is calculating. Okay. With the help of this particular vector calculation, it is creating this score, and based on the score value, it is giving the attention to that specific word. Let's say we are having two words, thinking and machine. So it will give the more attention to the thinking word. Now see, after getting this code, what it will perform? It will perform this softmax operation. Now see, what will happen? You are getting this code. Now this score would be divided by 8. Okay, that means you will divide this score by 8. Now if you divide this number, you will get 14. And if you divide this number, okay, you will get 12. Now we'll just calculate the softmax. Okay, I think you know the softmax. Okay, softmax is an activation function. It's an equation of the probability score. And if you just add this probability score, you will see that it would be 100% probability. Okay, always. So here you are getting actually 88%, and here you are getting only 12%. That means it is giving more attention to the thinking word. That means 88% attention it is giving to the thinking word, and only 12% attention it is giving to the machine word. Now I think it is clear how it is giving the attention to a specific word. Now in the 6th step, what will happen? See, I think you saw we are getting the softmax output. Now with this softmax output, what it will do, it will try to multiply this value. That means the value I think you are getting, remember this particular value. So it would be multiplied. And after multiplying, you will get one vector called v1. And again, it will perform for the next word as well. So here you will get v2. Now let's see you are having multiple words. So for all the words, actually it will do the multiplication with the value. So here he only used 2 words, but you can consider more than 2 words as well. Okay, the working mechanism will remain same. Then after getting this v1 and v2, what it will apply? It will apply the summation operation. That means it will sum up these 2 vector, and you will get z1 and z2. Okay, and now I think you remember what is this z1 and z2. So let me show you that high level architecture. Here, see, this is the z1 and z2. That means this z1 and z2 is the output from the self attention. Okay, self attention layer. And how self attention is working? As of now, whatever discussion I have given you, whatever, let's say, operation I showed you, this is the work of self attention, and that's how actually it will perform all the mathematical operation, and it will return z1 and z2, and this z1 and z2 will pass to the next, okay, next layer. Okay, next layer means I think this layer, yeah, to the feed-forward neural network. Okay, this is the idea. Now whatever I have discussed so far, if you want to see as a matrix representation, see the same thing. That means you are getting your input. Okay, you are getting your input. That means here we are giving our input. It will first of all convert it to the vector representation. Then it is generating some weights. Okay, WQ, WK, and WV, I think, remember. Then we are getting query, keys, and values. Okay, then it was multiplying this query with keys. Okay, and we are dividing with 8. Okay, and we are calculating the softmax. Okay, and softmax. And after that, whatever softmax output we are getting, we are performing the addition operation with the values. Okay, and it will give me Z. Okay, Z. That means the output. Now, so far, whatever actually operation you saw, this is for actually single head attention. Okay, single head attention. That means only one self attention. Okay, only one self attention mechanism. Now, inside transformer architecture, they're using something called multi-head attention. You can see. So here is the term called multi-head attention. So what is multi-head attention? See, if I show you this graph again, see, if I'm considering it, that means it is giving attention to the animal did. Okay, these are the word. Even you can see it is also giving some attention to this word as well. But see, this thickness is like very, less here, because it is not able to give the proper attention to this word. Okay, because it is using only single head attention. Okay, and it is only using this 3 weight. Okay, this 3 weight is not enough. Let's say you are having huge amount of data. Your input length is very big. that time actually only this 3 vector is not, only this 3 weight is not actually enough. So for this actually what we have to do, we have to apply something called multiple actually weights. Okay, and if I want to apply multiple weights, so what we have to do, we have to use something called multi-head attention. So Google introduced actually multi-head attention. So they're telling instead of only using one head, okay, one head attention, so they're telling instead of using only single head attention, we'll be using multi-head attention to perform the same operation. That means what will happen, see, this is the attention head 1, that means single head attention, and you will be taking another attention head. Okay, so this is called attention head 1. That's how we'll be taking another attention. And how many attention head it will be taking, I'll tell you. As of now, let's try to consider we are having multi-head, that means only 2 head. Okay, 0 and 1. Now the same thing they are doing, that means they're generating these weights. Okay, also this side also they are generating the weights, and the same operation would be happening as here as well. That means the operation I showed you now previously, the same operation will be happening here as well. Now you can ask me what is the main objective to perform this multi-head attention, because if you see in the transformer architecture, we can give very big size input. Let's say my input prompt would be very big. I think you saw in the ChatGPT, we can pass a very bigger prompt. Okay, very bigger prompt to the this one, our ChatGPT input, right? That means to my GPT model. So how it is processing that particular bigger input, because it is using this multi-head attention concept. That means with the help of multi-head attention concept, it is able to give the attention to all the specific word actually present in that particular prompt. Okay, so this is the main idea. That means if you're only using single head, it won't be able to handle that particular bigger prompt. That's why you have to use multi-head attention here. Okay, always this is the main concept. Now see, that's how actually things are working. Let's say you are passing 2 words, thinking and machine. So you are passing as a vector representation. So this vector will go to the different attention. And now here you can see they're using 8 different attention heads, 8 different attention heads. That means whatever things we have learned so far, we have learned for only one head, one self head attention, right? Well, self attention. Okay, but they're using something called 8 different self attention, 8 different self attention. Here you can see, okay, attention head 0, 1, ... 7, because it is starting from 0. That's why it is ending till 10. Now if you count it, they're using something called 8 different attention head here. Okay, so inside 8 different attention, all the calculation is happening. After that, whatever Z0, Z1, Z3 they are getting, they are doing the summation operation. Okay, and this is your final vector. Okay, this is your final vector. That means the Z. That means this one. Let me show you. This one. Okay, now inside that they're using 8 different self attention, and this is the Z1 output you are getting. Okay, I hope you got it. Now see how beautifully JLMR created this blog. How beautifully he has used all the visualization. Okay, so to explain this particular concept. So that's why I feel like this is the best resources for the transformer. Okay, if you want to understand, you can use this particular blog. Now I think we have understood till here. That means we are getting the Z. Now see, if you see the entire architecture, that's how it is working. So you are having the input, you are it is initializing the weights. Okay, so it is generating the weights for 8 different actually self attention. Okay, then you can see the query keys values, then the Z. Okay, that means the output from my self head attention. Then it is concatenating all the vector, and we are getting only one vector, which is nothing but Z. Now see, after using multi-head attention, that is how your output looks like. Now see, it is able to give the attention to all of the word actually it needs. Okay, to represent this particular it right now. Now see, this line is more darker right now. Okay, this line is more darker. That means it is performing better than previous. That means previous we are using only one head attention. Now we are using multi-head attention, and the performance is very good right now. Okay, this is the main idea. Now see, he has captured some of the images. Okay, experimental images you can see here. Now let's try to understand another important things. I told you now. So let's say whenever we are using any, let's say traditional embedding model, let's say TF-IDF, word to wake, or let's say any other embedding model, let's say this one, bag of word. So it won't be able to capture the semantic meaning. Okay, semantic meaning of a sentence. Let's say here we are having a sentence. This is the, let's say, French sentence. Z Swiss A to the end. I don't know how to spell, but let's say this is my sentence. Now after Z, this particular word is coming. After this word is coming. Okay, how it will remember? That means how it will understand the contextual meaning. That means the sequence meaning. Okay, sequence meaning of a sentence. So to understand that sequence actually meaning, they're using something called positional encoding. Okay, positional encoding. Now let's try to understand what is positional encoding. See, let's say this is my input. It is converting to the vector. Now you can see this particular vector they are adding with the positional encoding. Positional encoding is nothing but it's a vector only. Okay, it's a vector only. You can see T1, T2, and T3, and they're doing the addition operation. Okay, after that they are getting the embedding with the time signal. That means whenever we write any kinds of, let's say, sentence, let's say my name, okay, is Bappi. So it always follows one time sequence. Let's say my I have written at the time of T1, name I have written at the time of T2, is I have written at the time of T3, and Bappi T4. Okay, that's how it follows one sequence. Okay, so that's why text data can be also called as sequential data. Okay, it's a sequential data because it follows the time. Okay, so that's why they are telling embedding with the time signal. That means whatever input you have given, okay, whatever input you have given, it is having one time. Let's say T1, T2, and T3, and so on, right? So on. So with that, they're adding this positional encoding. Now, how this positional encoding helping us to identify whether after Z, this word is coming, after Swiss, this word is coming? Because if you see, positional encoding nothing but it's a vector. Okay, and after adding this vector with my embedding, so again we are getting another vector, yes or no? Okay, now if you calculate the distance, okay, between these three vectors, you will see that this vector and this vector would be closely together, because if you just do the subtraction, okay, if you just find the distance, you will see that you will get very less distance between these two vectors. Okay, and you will see that this vector and this vector distance would be more. Okay, because you can see the number. Okay, so that's how actually it is identifying after Z, this particular word is coming, after this word is coming. Okay, based on this particular vector. Okay, that's how they're doing distance calculation, and they're trying to understand the sequence information of a sentence. Okay, let's say after my Bappi is coming, after my name is coming, after name is coming, after is Bappi is coming. Okay, I hope it is clear. So that's how they're handling this particular sequence. Okay, now I think you got it. Whenever we are passing any kinds of bigger prompt to the large language model, how it is identifying that particular contextual meaning, how it is remembering that particular sequence. Let's say after this sequence is coming. Now he has added some more graphs. So as of now, let's skip. Okay, it's not required. Okay, now the next thing we'll be discussing about the residual block. Those who have learned about like computer vision, so I think you learned one model called ResNet. Okay, so in ResNet also we had this kinds of architecture. Okay, I think you remember. So I think you remember. So let's say here we are having different layer. Okay, different layer. Fine. And we also had something called residual block. So that's how actually it will look like. That means whatever input actually you give usually. So sometimes, let's say if this block is not working good. Okay, let's say this block is not working good. Not good. Then what will happen? It will skip this block and this output will go to the next block. Okay, this is called actually skip connection. Okay, skip connection. Okay, and this is called actually residual block. So we already learned this residual block in our CNN architecture. So the same residual concept has also applied in this particular transformer architecture as well. So here we are also having residual connection. You can see, let's say this is the input we are giving. Okay, let's say if this particular self attention layer is not working good, what will happen? This input will go to the next layer. Now they're also using something called add and normalization. And what is normalization? I think you know, with the help of normalization, we just bring our data distribution in a normal. Okay, normal distribution. I think you remember, right? This is whatever weight actually we're having. So if you just visualize them, you will see it will be a normal distributed. Okay, normal distributed output. So it helps us during backpropagation whenever it will try to find the global minima. Okay, that time actually this concept helps a lot. Now you can see again we are having another residual block connection, skip connection. Okay, so that means if any of the layer is not working good, this will actually skip this part and it will go to the next layer. So this is the idea of the residual connection, because it's a very huge layer. Because you can see this transformer architecture, it's a very huge layer. So sometimes, let's say if you are using any simple data, very simple data, so you don't need all the layer. You don't need all the layer to process your let's say input. So sometimes whenever you are having the simple data, it will go to some of the layer and it will perform better. Okay, that time actually it will skip. These are the, let's say, layer. Okay, so this is called actually skip connection and residual block. And if you want to see the normalization, how it is performing the normalization, so here you can see the normalization. So it will do the addition operation x and z, okay, z vector, and it will perform the normalization like that. Okay, then whatever output it is having, it will pass to the feed forward, and feed forward again will pass to the add normalization, and again it will pass to the next layer. This is the idea. Now here you can see the entire architecture, guys. So far whatever we have discussed, now he has given inside one block only. Now we are giving our input, we are adding the positional encoding, then self-attention, then we are also adding something called add normalization, then it will pass to the feed forward, then add normalization again, then it will pass to the next encoder. Okay, and inside that we are also having some residual connection. Okay, then whatever output we are getting, okay, let's say whatever, let's say encoder we are using, like I think I showed you 6 encoder layer we are using. So this output will go to the decoder. Okay, now see, directly it is going to the decoder layer. Now at the same time, this output is also going to the encoder and decoder attention. Now you can ask me, what is encoder and decoder attention? See, this is the same, whatever things we have learned, encoder and decoder, the same architecture they're using in this particular layer. Okay, that means whatever output you are getting here, again passing to this particular encoder and decoder, again it will process those are the input and it will pass to the next layer. Okay, so that's how actually your output is passing to the encoder and decoder as well as the decoder. And how many decoder we had? We had 6 decoder layer. Now let's try to see the decoder side. Now see, here we are passing the input. So this is the input we are passing to the encoder. Encoder will pass this output to the decoder. But before passing this output, it will add some vector. You can see K vector and V vector. Okay, it will first of all multiply, then it will pass to the decoder. Okay, and decoder will pass to the linear and softmax. That means it will apply the softmax function on top of it. Now one thing will happen, let's say if you are doing actually language translation, so the input you are giving to the encoder, so this output actually you are passing to the decoder, and decoder will predict something. See, decoder will predict something, it will generate something, let's say I. So you are giving French input and you are getting English output. Let's say Z means I, Swiss means am, and educant means student. Okay, so that means it is, first of all, see, if you see the first iteration, let me show you. It's an animation. If I show you the first iteration, see, this is the first iterations. First of all, it is predicting I. So this I, again, it is coming as an input to the decoder side. You can see I. Then it is predicting am. Again, this am will go to the input of the decoder side. Okay, then it will predict something called A. That means based on these two words, it is predicting the next word. Okay, based on these two words, it is predicting the next word. Okay, I already showed you now that LLM concept, like it will predict the next word always. Okay, that's how it is predicting the next word. Okay, unless and until it is having the EOS sign, that means end of the sentence. Okay, EOS. Okay, this is the tag, I think you know. Okay, what is EOS? And there is another one called SOS. Okay, start of the sentence and end of the sentence. Whenever it is getting the tag, that means this sentence is complete and it will stop the execution that time. Okay, so that's how your encoder and decoder is working. Okay, and inside encoder, whatever things we are having, I already explained. Inside decoder also, whatever things you have, I already explained. Okay, that's how it is actually building one amazing architecture called transformer. Okay, transformer, and that is why transformer is so powerful, because it is having so many components inside that. It is using something called multi-head attention. Okay, that is the main concept here. So this is the entire understanding, guys, and I hope, guys, you got the high level understanding of this transformer, like how it is working and what is the internal mechanism of the transformer. Now if I open the actual architecture in the paper, now I think you will get it. See, this is the encoder side. Okay, this is the encoder side, and now I think you know what is input embedding and what is the positional encoding, what is multi-head attention, what is add normalization, and what is these are the arrow. That means this is the skip connection residual block. Then feed forward again, add normalization. Again, you are passing to the multi-head attention, and you are also passing this in output to the decoder side. You can see this is the decoder side, and inside decoder we are having multi-head attention again, add normalization, multi-head attention, feed forward. Okay, softmax and so on. Okay, and whatever output you are getting, you are again passing this output to the input of the decoder input. Okay, this is the idea. Now I think this architecture is clear how they have developed. Okay, now you simply just try to go through this paper once, just try to read, or you can also read this particular blog. Okay, so it will give you the clear-cut idea about the transformer architecture. Okay, so this should be my suggestion, guys. Please go through one time this particular blog, just try to read everything. Okay, see the way actually he has written, if anyone is from college background, they will also able to understand. Okay, that much easy it is. So yes, this is all about our transformer intuition. I hope you got it, how transformer is working. So based on this transformer, today's actually whatever large language model we are having, they have developed. Now in the next video, we'll be learning about like how ChatGPT got trained, because you can see ChatGPT. So ChatGPT is using one large language model called GPT. Okay, so we'll be understanding how ChatGPT actually they train, like what is the internal mechanism of the ChatGPT. Okay, we'll be discussing this part. So I think you are already familiar with ChatGPT, right? So ChatGPT is a product of OpenAI. So inside ChatGPT, we can pass any kinds of prompt and we can get the response. So it is kinds of conversational, let's say chatbot they have developed. But by that particular chatbot, what you can do, you can perform all kinds of NLP tasks. I think I showed you one example. I think you remember. We can perform language translation, text summarization. We can also perform sentiment analysis. Okay. We can also, let's say, generate the codes. Everything is possible, because I already told you, na, LLM, why it is powerful? Because it can perform multitask, right? Multiple tasks it can perform with the help of one model only. Task wise, it is clear like how it will able to perform that task, right? But what about the conversational agents? Let's say whenever I'm passing any kinds of prompt, how it is identifying, okay, how it is identifying what kinds of, let's say, prompt I'm giving, and what kinds of tasks actually I'm expecting from my ChatGPT. Okay, so this is what actually will be understanding in this particular video, because if this understanding is clear, so going forward, whatever model you'll be learning, whatever application you'll be building, this would be more clear in your mind. So first of all, you have to remember one thing. See, ChatGPT is not a model. Okay, so ChatGPT is just an application. Internally, it is using a LLM, which is GPT 3.5 or GPT 4. It has trained on large amount of data, which is also available over the internet. That means over the internet till 2023, whatever actually data we are having. So all the data they have used to train this GPT 3 or GPT 4 model, right? Now to train this ChatGPT, they actually follow 3 steps. The first step is generative pre-training. The second step is supervised fine-tuning. And the third step is reinforcement learning. I'll discuss all of them one by one, no need to worry. But first of all, just try to see, as I already told you, ChatGPT is not a model. It's just an application. It's just an interface, right? So whenever you are giving any kinds of prompt to the ChatGPT, it is using one OpenAI API key, right? I think you know what is OpenAI API key. With the help of OpenAI API key, it is sending that particular request to the model. You can see it can access different model of the GPT, like GPT 3.5, GPT 4, okay, or any other model actually GPT is bringing in future, right? So this is the idea. Let's say you want to perform language translation. You are giving the prompt here. So this ChatGPT interface receiving your prompt, then it is sending that particular prompt to the model with the help of OpenAI API key. That is the idea. Okay, so that means ChatGPT is an application, and it is using internally it is using some kinds of LLM, which is known GPT-4 or GPT 3.5. Now, as I already told you, they used actually 3 steps to train this model. Now you can see the first stage is generative pre-training. So here you can see this base model GPT trained on a bunch of stuff from internet for a whole bunch of different things by using the transformer architecture. That means they're using a transformer architecture internally, and they're training on top of the internet data, okay, or internet documents data you can talk about. Then they are getting something called base GPT model, okay, base GPT model. Then this base GPT model, then again they are doing something called supervised fine tuning. Okay, in this stage 2 they are doing supervised fine tuning. So what is supervised fine tuning? I'll discuss everything, no need to worry. So next, with the human AI trainers, you get to have conversation where they play both sides, you and AI assistant. Okay, now after performing the supervised fine tuning, they get one model called fine tune ChatGPT model. Now they'll be performing something called reinforcement learning through human feedback. So here you can see next, let's take the model to the next level by optimizing its even more reinforcement learning by training it against a reward model. Okay, that means they will be creating something called reward model. And why they'll be creating the reward model, I will tell you. Then after that, they will be getting the ChatGPT model, and this is what actually we are using. Okay, this is what we are using in our day-to-day life. This is the idea. Now let's discuss all the stages one by one. Now first of all, let's try to discuss generative pre-training. Okay, now see, what is generative pre-training? As I already told you, they're using a bunch of data from the internet and they're training one transformer model. Okay, so they're using the code transformer architecture only. On top of that, they're adding some more layer. Okay, and they're creating one GPT model. Okay, this is called a GPT model. Now this model will be able to do actually various kinds of tasks like text summarization, sentiment analysis, sentence completion, translation, and so on. But what is our expectation from our ChatGPT? So here user can pass any kinds of prompt. He or she can chat with chat and conversation with this let's say application, yes or no, right? But after training this particular, let's say, transformer model, we are only getting the actually task output. Let's say this model only can perform text summarization, sentiment analysis, sentence completion, and language translation. Apart from that, actually, it can't do anything. Let's say it can't do the chat conversation with the human. Okay, this model can't do. So this is our expectation. Okay, with that, this is our expectation. So for this, actually, what they did, actually, they followed another stage called supervised fine tuning. In supervised fine tuning, what they have done, So they have actually taken two human. So one human called human agent acting like a bot, another human, the actual human agent. Okay, that means both are human, but one human actually will act like a bot and another human will act like a human only, right? So this particular human will give some request. Okay, let's say he will put some, let's say, text, let's say, how are you? So this human will give the reply, let's say, I'm fine, what about you? Again he will give, I am also fine. Then he will tell, I need help from your side. This particular, let's say, human will tell, so this particular human will tell how I can help you. Okay, so that's how actually they will be doing the conversation, the way actually we do the conversation with our chat GPT. Okay, so initially we have to create our data, that means chat data. Okay, chat data. So to collect the chat data, they're using this particular technique called supervised fine tuning. Okay, supervised fine, they're supervising the model. Okay, this is the main idea. Now see, after doing these kinds of conversation, you will have different data. Let's say from the human side, you will get lots of requests, and from the bot side, that means human agent bot size, you will be getting lots of response. Now you'll be using this particular data to train again your base GPT model. Okay, you will be again fine tuning your base GPT model, and you will be using something called stochastic gradient descent optimizer. Okay, SGD optimizer they are using, and they're training one model called SFT ChatGPT model, that means supervised fine tuning model. Okay, this is the main idea here, and this is called actually SFT and supervised fine tuning. But one issue actually they observed after doing the supervised fine tuning, this model can only perform related to the training data. Let's say if someone is giving any kinds of input which was not present in the training example, at that time this model was giving some random output. Okay, so to actually overcome this issue and to make this particular model more good, they followed something called reinforcement learning through human feedback technique. So inside reinforcement learning through human feedback, what they are doing, whatever, let's say, conversation having between this human agent and SFT chat GPT model, so they're trying to rank the results. Okay, rank the response. You can see, let's say this SFT model will give actually multiple response. Now there would be a human. Okay, there would be a human agent. So this human agent will rank the result. Let's say here we are getting 1, 2, 3, 4 different response. Let's say A, B, C, and D. Now between these 4 results, which one is the good? Okay, which one is the good and which one is the, let's say, suitable with the user input user has given. Now he will just try to rank the results. Now let's say B response is good, then A, then D, then C. Okay, this is the rank response. That's how actually he will try to prepare. Then what they have done, they created one reward model. And what is reward model? Reward model is nothing but it's a reinforcement learning model. Those who are familiar with reinforcement learning, I think you know what is reward model. So here you can see they're giving actually different response, and they're actually generating one score. Okay, like what is the score for this response? What is the score for this response? Okay, that's how they're generating the score. Now whoever actually having like more score, this particular response would be considered as my final output. Okay, that's how actually they're doing reinforcement learning through human feedback, and they're improving the accuracy of the model. This is the main idea. That means if you see in high level, so you are using reward model and you are ranking this particular, let's say, response based on that and based on that actually you are providing the actual response, and this reward model will give some policy. Let's say if this response is good, if user is liking that particular response, so definitely it will give some reward, otherwise it won't be giving any kinds of reward. So sometimes in the chat GPT will see that it will ask for your feedback whether you are getting the correct output or not. If you give the, let's say, low rating, that time they will consider this model is not working good, that time they will give negative reward. So again this reinforcement learning will automatically learn, okay, how to improve the quality of the model. And if you are giving positive feedback, that means it will give the positive reward that time. Okay, so that is how actually reinforcement learning works. So here in the environment, you just put one agents, that particular agents learn the environment, and whatever activity you are doing, it will try to learn, and based on that it will try to update the reward model. This is the main idea, right? So yes, this was the actually core concept to train this chat GPT model. And that's how actually not only we get that task specific model, we can also perform the conversation with that particular model. Okay, because they have done, because I think I showed you now how they have done this particular entire strategy and how we can perform the conversation. So whenever we are giving any kinds of prompt, first of all, it will try to understand my prompt because of that particular supervised fine tuning. Let's say I'm giving a prompt, I want to do the language translation French to English. So it will try to understand that particular prompt. Then based on that, it will decide what kinds of task you want to perform. Okay, apart from that, if you are doing some casual conversation also, it can also handle. because again it was trained with huge amount of data. Okay, that's the idea. So yes guys, I hope this makes sense now and you got how ChatGPT was trained. And now this concept will help you to understand whatever, let's say, model will be understanding in future. Okay, so I think you enjoyed. So if you don't know about Hugging Face is a platform. So with the help of this platform, you can do generative AI project, you can do NLP project, even you can also perform computer vision related project. So here we are more focusing on the generative AI. So we'll be using this Hugging Face platform for the generative AI related task. So this Hugging Face platform is having all kinds of large language model. Even it is also having so many datasets you can use to train these kinds of large language model. And Hugging Face provides one pipeline. So with the help of this pipeline, you can easily perform any kinds of task. And Hugging Face is also having one Python library called Transformer. With the help of Transformer library, you can easily implement any kinds of generative AI based project. So let me show you this Hugging Face platform. What are the things it is having? So guys, if you want to open the Hugging Face platform, just search for Hugging Face. Okay, Hugging Face in Google. You will see this first link. Just try to open it up and make sure you create one account here. So for me, I already have one account. So what I will do, I'll just try to log in with my account. So if you don't have the account, you just need to do the sign up operation. Okay. So with your email address, you can also create an account. So let me log in with my account. So guys, as you can see, I already logged in with my account and this is the interface of the Hugging Face. Now, as I already told you, Hugging Face is a platform. So with this platform, you can perform lots of tasks. You can perform generative AI related tasks. You can perform natural language processing related tasks. Even you can also perform computer vision related tasks. Okay, even you can also do audios kinds of tasks. Let's say you are having audio data. Okay, you can also do these kinds of tasks in this Hugging Face platform. Okay, now it is having actually different services. The very popular services it is having called models. That means this Hugging Face is having all kinds of large language model. Let me show you. If I click on the model section, now see, it is having that many of model. Just try to see the count. That many of models are available, and these are the models are completely open source. So you don't need to pay here. Okay, if you want to use these are the model, you don't need to pay here. Only you just need to use Hugging Face Python library for this. Okay, with the help of Hugging Face Python library, you can easily access these are the model. Even I will also tell you how we can access different open source large language model and how we can implement different application on top of it, right? Now, if you see left hand side, it is having different tasks. You can select the multi-model. That means if you want to generate image text to text, if you want to do visual question answering, if you want to do, let's say, document question answering, if you want to, let's say, do video text to text, everything you can perform here. Then it is having computer vision related tasks. You can perform object detection, image classification, image segmentation, text to image. Okay, all kinds of computer vision related tasks are available. Even nowadays, whatever multi-model you can see, let's say large language model will generate image, large language model will generate videos. These kinds of models are also available in this Hugging Face platform. Now you can see it is also having natural language processing related tasks. That means you can perform text classification, token classification, summarization, feature extraction, text generation, code generation, everything you can perform here. Okay, apart from that, I already told you it is also having some audios model. Let's say you want to perform text to speech, text to audio, okay, automatic speech recognition. These are the tasks also you can perform here. Apart from that, it also provides tabular kinds of tasks. Let's say you can perform tabular classification, tabular regression, time series forecasting. These are the tasks you can also perform. Then they have added another amazing technology, the reinforcement learning. So those who are interested in reinforcement learning, you can also perform reinforcement learning operation with the help of Hugging Face platform. So it is having all kinds of reinforcement learning model. You can also perform something called graph machine learning with this Hugging Face platform. So here I'm not going to focus on all the actually task here because we are more focusing on the generative AI, and for generative AI actually we'll be more focusing on the NLP, that means natural language processing, and we'll be focusing on the multi-model section. Okay, because it is having different large language model, as I already told you. Now you can select any kinds of task. Let's say you want to perform, let's say this one, you want to perform, let's say a text classification. Okay, just select the text classification. Now see, automatically it will suggest you all the text classification related model. Now see, these are the model from different organizations. See, this model is from Meta AI. Okay, Meta Llama. See, with the help of Meta Llama, you can also do text classification. And this is one of the large language model. It is having 86 million parameter. And this is the download. See, this is that many times actually this model got downloaded. Okay, so you can also download this model if you are let's say you like this model. You can also start this, you can also like this. Even they have already given the model card. Let's say you want to read about this model, like what this model can perform, how many parameters it is having, what kinds of data it got trained. Okay, everything they have given. Okay, everything they have given. Even they have also given the code snippet you can use. Okay, let's say you want to test this model, you can copy this code snippet and you can execute it here. Okay, so it's one of the amazing platform, guys. If you are working in the field of generative AI, so definitely you should learn the Hugging Face platform. And no need to worry, everything I'm going to teach you here. So let me show you what are the things we'll be discussing here. See, inside Hugging Face, actually, Hugging Face, we have to learn some of the very important concept. The first concept, we have to learn the pipeline, because inside Hugging Face, everything is all about pipeline. Okay, whenever you will be using one Python library of the Hugging Face called transformer. Okay, transformers. See, transformers is the architecture, but they have also named it as a library. Okay, because it is having all the model which is based on the transformer architecture only. So that's why they named this particular library as a transformer library. Okay, so inside transformer library, whenever you will be writing the code, let's say you want to perform language translation, summarization, you have to create a pipeline for this. Okay, so we have to discuss the pipeline. Then we'll be discussing different NLP tasks you can perform with the help of this Hugging Face library. Then we'll be discussing very important concept called tokenization. Okay, because in Hugging Face, everything is all about tokenization. So whatever pre-processing, whatever text representation you have to do with the help of tokenization only. Then we'll be discussing about the dataset, like what are the dataset it is having. Then we'll be also discussing about another super important service called Spaces. Let's say you don't have good configuration PC, but you want to train one large language model. So what you can do, you can also take the Hugging Face Spaces. That means Hugging Face infrastructure, but definitely you have to pay for this. So there actually you can train any kinds of large language model. Okay, and this machine is like very good configuration machine you can take there. Then the fifth topic we'll be discussing about fine tuning. Okay, fine tuning LLM. Okay, with the help of Hugging Face. That means we'll be learning how we can fine tune any kinds of LLM. Okay, with the help of Hugging Face platform. Then at the last we'll be seeing some of the project implementation. Okay, so with the help of Hugging Face, we'll be doing some of the project implementation. That means we'll be doing text summarization, language translation. Even we'll be also doing the research paper summarization. So these are the projects we'll be implementing one by one. So I hope this is enough to know about Hugging Face. And if you understand these are the concept, definitely you can use Hugging Face platform if you want to build any kinds of application, okay, later on. And trust me, guys, if you want to use open source large language model, that means Open LLM, okay, Open LLM. So Hugging Face is the only way, okay, you can use Open LLM. Okay, Hugging Face is the only platform. It will help you to work with the open source large language model. But if you want to work with paid large language model, let's say if I want to take any kinds of commercial large language model, that time you can use something called OpenAI. Okay, OpenAI platform. Even there are some cloud platform as well. Let's say Bedrock is there. Okay, Amazon Bedrock is there. Then Vertex AI is also there. So we'll be also learning these are the things one by one. No need to worry. First of all, let's try to understand the Hugging Face, because this is the starting point. Okay, this is the starting point in the field of generative AI. So what I feel like, if you want to understand the generative AI, if you want to understand the large language model, if you want to let's say use them as a practical, so I will suggest first of all start with Hugging Face platform, then try to learn OpenAI and whatever services you are having. Okay, everything I'm going to teach you, no need to worry. Okay, so apart from that, it is also having datasets, guys. As you can see, different datasets. Let's say you want to train one language translation model. So simply you can select the task here. Let's say I want to do the language translation. I'll select the task here. So this is the translation. Now see, these are the data related language translation. Okay, see, these are the data related language translation. So it is having all kinds of language translation data, you can see. So see, this dataset is containing Canadian actually text as well as the English text. That means you can perform Canadian to English, otherwise English to Canadian, I think. Okay. Apart from that, you are having different dataset. Even you can also search here. If you want to, let's say, find any kinds of dataset, you can also search here. It is also possible. Now, apart from that, you can also select different libraries. Let's say I want to perform one task. Let's say I want to find a model. Let's say I want to perform something called text classification. Now I want to use one specific library. So see, it is having different library. You can use PyTorch, then you can use TensorFlow, then you have Safe Tensors. Okay, then you are having Keras, different library it supports. Let's say I want to perform with the help of PyTorch. Okay, PyTorch framework. So these are the model related PyTorch. So if you want to use these are the model, you have to use PyTorch code. So similar wise, if you want to perform with the help of, let's say, TensorFlow, you can select the TensorFlow. It will give you all the model related TensorFlow that time. Okay, that time you have to install TensorFlow library. Okay, not the PyTorch library. So that's how it has given different flexibility, different functionality, so that you can filter out the specific model, filter out the specific data. Okay, everything you can do here. And it is having another amazing service, as I already told you, the Spaces. So Spaces will give you, let's say, this infrastructure. If you want to train any kinds of large language model, you can use their Spaces service. So there you can buy their instance and you can train your model. See, it is having different spaces. Even you can also create your own spaces. Now, apart from that, it is having another amazing documentation. Now, see, if you want to deep dive in this Hugging Face platform, like how you can use this Hugging Face platform properly, so they are also having their official tutorials. If you just go to the documentation, so they are having one documentation, and inside that you will get one section called task. Now let's click on the task. Now see, let's say I want to perform image classification task, so I'll just simply click here. Now see, it will give me the official tutorial. So they have their all the YouTube videos. You can also refer the YouTube videos. Even you can also refer their blog. Okay, how we can perform the text classification that time. Sorry, how we can perform the image classification. So everything they have written here. Okay, so this is one of the amazing, actually, let's say, platform I personally prefer if I want to implement any kinds of project, and if I want to learn anything. Let's say I don't know about, let's say, zero-shot image classification. I'll come here. I'll go to the tutorial section and easily I can learn, okay, how we can use this particular model. Okay, so that's how actually you can also deep dive. But if you cover this video, I hope you will be learning everything about this Hugging Face platform. But still, if you want to deep dive, you can refer their tutorial as well. Fine. And if you want to take the premium subscription, you can also see their pricing and all. You can also check it up. But as of now, premium subscription is not required. We'll be using free services. Okay, free services is enough for us, because here we'll be only accessing the models dataset. Okay, these are the thing. As of now, I'm not going to take the spaces. Everything I'll be doing in my Google Colab, because in Google Colab we'll be getting free GPUs. Okay, that is the idea. So yes, guys, this is the introduction of the Hugging Face. Now I think you got it, what exactly this Hugging Face is, and we saw like different services of the Hugging Face. Now in the next video, we'll be doing some hands-on on top of the Hugging Face, like how we can use the Hugging Face with the help of Python programming. So there we'll be installing one amazing library called Transformer. Okay, with the help of Transformer, we'll be using the Hugging Face. And it is also give you the API functionality, guys. If you want to take the Hugging Face API key, you can also take. For this, you have to go to the settings. Now here you are having something called access token. Okay, you can also take the access token. So with the help of access token also, we can access the model. Let's say some of the models you will be getting here, those models actually you can't directly download. For this, you need this Hugging Face access token. Okay, so we'll be also learning how we can use the access token to access any kinds of model, and how we can generate these are the access token as well. Fine. So here I already created one collab notebook, and here I have already mentioned each and everything you need for the Hugging Face. Okay, practical understanding. So as I already told you, if I want to use Hugging Face platform with the help of Python, we need to install one library called Transformers. Okay, so this is the library. So Transformers library is having all the functionality present inside the Hugging Face platform, right? So if you want to install Transformer library, so you have to execute this command called pip install transformers. Okay, now let me first of all connect this notebook, and the resources would be shared, guys, in the resources section. So from there you can download and you can also code with me. Okay, it is connected now. Now the first thing what you have to do, you have to select the runtime to GPU. Okay, because I'm not going to use the CPU configuration machine here. I'll be taking the GPU machine, because here we'll be using large language model. So definitely you have to select the GPU based machine there. Fine. So let me select the GPU machine. And if you're using free Colab, you'll be getting T4 GPU. And if you're using Colab Pro, there also you can take actually different. See, let me show you. If I click on change runtime, see, you can also take A100 GPU and L4 GPU as well. Okay, these are the GPU you can also access. So now, guys, you can see my notebook is connected. Now, if I want to check the GPU, you can execute this command called NVIDIA, okay, -SMI. So this will show you the GPU configuration you got. So here I'm using free Colab, that's why I got Tesla T4 GPU. Now, first of all, I have to install the Transformer library here. See, Transformer is already installed. Now, see, inside Hugging Face, we are having different tasks, as I already showed you. So if I, let's say, click on the models, and if you see the left hand side, you can see you are having different tasks. So here you are having different tasks. Let's say here we are focusing on generative AI, that means the natural language processing. So here we can perform different tasks. Let's say we can perform text classification, token classification. Okay, all kinds of tasks actually you can perform. Whatever task actually you see in the field of NLP, or in the field of, let's say, generative AI, all kinds of tasks you can perform here. So if I want to perform these are the tasks, I have to use one functionality from the Hugging Face called pipeline. Okay, So here you can see I have imported this pipeline from the transformer. Okay, so it is available inside transformer. Now let's say we are having various NLP tasks, as I already showed you, text classification. Then we are having here you can see text classification, token classification, table question answering, zero shot classification, translation. Okay, now see I have listed down all the tasks here. Now let's say if I want to perform text classification, so what you have to do inside pipeline, you have to mention I want to perform text classification. So this transformer library, what it will do, it will automatically try to understand you want to perform text classification. So all the code actually it is having in the backend, it will execute that particular code snippet. That means it's a high level wrapper. Okay, on top of, let's say, Hugging Face, it's a high level wrapper, this particular transformer library. So you don't need to write the code from scratch. Let's say you don't need to write the code, I want to perform text classification. So code you don't need to write from scratch. Only you just need to give this particular input to the pipeline, and pipeline will automatically take care. You have to do the text classification task. And for this, whatever, let's say, strategy you have to follow, everything, it will take care. Okay, I hope you got it. Now see, similar wise, if you want to perform token classification, you can mention token classification. If you want to perform question answer, you can also give question answering. If you want to perform text generation, summarization, translation, even also you can select the model. Let's say which model you want to use. As I already showed you, now we are having so many model. Now let's say I want to perform translation. Now see, you are having different model. Okay, different model. Now see, you can also give the model. Okay, model ID. Now let's say I want to use this model. I'll just click here and I'll copy the model ID. This is the model I'll copy, and here I just need to mention. So it will automatically download this model from the Hugging Face. So you don't need to manually download it as well. So that much powerful it is. Okay, so that is why I told you you have to master this pipeline concept, because going forward, whatever actually, let's say, application you'll be implementing, you need this particular pipeline approach. Fine. Now see, I have given different actually example, a computer vision example also. Let's say you want to perform image classification in the pipeline, just mention image classification. Okay, even also you can specify the model, it's up to you. Now see, different example I have given just for your reference, so that you can refer this notebook later on. Now let's perform one specific NLP task. Let's say I want to perform sentiment analysis. So here you can see the task, as well as you will also get the all kinds of tasks in the documentation section. So here you are having one tab called task. Now see, all the task is also visible. Read that, computer vision, natural language processing, audios, and multi-model. Okay, everything is there. Now let's say I want to perform sentiment analysis, and sentiment analysis is what kinds of task? It's a text classification task. I think you saw it's a text classification task. Okay, now either you can give the text classification. Okay, either you can pass the text classification here, either you can also give the sentiment analysis. Okay, both it will work. So I have given sentiment analysis. Okay, I want to perform sentiment analysis in the pipeline. Now it will give you one object called pipeline object, and this is my classifier. Now inside that you have to pass the input. Let's say here I've given the input. I was so not happy with the last Mission Impossible movie. Now this is the sentence I have given. Now see, if I execute this line of code, so it will automatically download one specific model. Now see, here I haven't given any kinds of model name. So it will download one default model, and it will try to predict whether this particular sentiment is a positive or negative. Okay, let me show you. See, if I execute this code, see, it is using one model, default model called distill BART based case. Okay, Finetune SST to English model. And this is the link of the model. If I open it up, see, it is using this model. This is the default model. Okay, and here is the prediction, guys. It's a negative sentiment, and it is telling 99% confidence it's a negative sentiment. Okay, that means it is performing amazing. See, that much actually it is easy to use this transformer library, and that's how actually pipeline helps us to perform any kinds of task I want to perform. So I don't need to write the code from scratch. Only I just need to mention that specific task name. It will automatically do it for me. Now there is another way you can pass the input. Let's say here is my pipeline. Inside pipeline you can mention the task I want to perform. Let's say a sentiment analysis, and the second parameter you can give the input. Let's say this is the input I have given. I was confused with the Barbie movie. Okay, now it will give you the same output. So either you can follow this approach, either you can follow this approach. This is the one line approach. Okay, so both it is possible. Now if you are having any big text, that time what you can do, you can also use multi-line actually string. There also you can pass the text like that. See, again it's a positive review, and this is the confidence score. Fine. Now let me show you how we can specify any kinds of model. So let's say now I want to perform sentiment analysis, and I want to use any other model. Let's say I want to use this model, Facebook BART large MLI. Let me search this model. You will see this is one of the large language model. You can see, but large MNLI. See, again, it's not a large language model. I can say it's a language model because this model only can perform one specific task, which is nothing but the sentiment analysis. But going forward, we'll be using large language model, like we'll be using Llama, Mistral, Falcon, Gemini. Okay, so these are the model actually we'll be using, and these are the model is multitasking model. Okay, that means large language model. So there are two kinds of models are available, guys. Just try to remember. One is the large language model, that means LLM. Okay, and this is like only LM, that means language model only. So language model can only perform one specific task. Okay, one specific task. And large language model can perform multiple tasks. Multiple tasks. Even it can also perform chat operation. Okay, chat operation, because I already told you na how large language model was trained. Okay, because of that supervised fine tuning, reinforcement learning through human feedback. These are the technique has applied. But whatever LM model you can see, it has only trained with the transformer architecture. Okay, transformer architecture. Okay, I think I showed you the transformer architecture example. I think you remember. Fine. So these are the model we are using. This is called actually language model only. It can only perform one specific task. So that's why here we are mentioning the task name sentiment analysis. Now see, here we are giving the model name. Now we can use any kinds of model. Just go to the model section. Go to the model section. Now let's say I want to perform sentiment analysis. For this I have to use text classification. Now just try to get any kinds of model. Let's say you want to use this model. Copy the model ID. Try to paste it here. Okay, it will download that model and it will do the operation. Now let me show you. See, first of all, this model will be downloaded from the Hugging Face. Now see, it is downloaded, and see the model size. It's around 1.63 GB. This is actually sentiment I'm getting. This a neutral sentiment. Okay, it's not a positive, it's not a negative, it's a neutral sentiment, and this is the confidence score you are getting. Fine, great. Now how to perform the batch actually sentiment? If you are having batch data, let's say multiple, let's say sentence, that time how you can do, you can use something called batch sentiment analysis. So again, just try to create a pipeline, and whenever you are preparing your input data, just try to give inside a list. You can see it's a Python list, and inside that I'm having different sentence. Okay, different sentence. Now you have to pass this particular list inside your classifier. Now see, it will take one by one all the sentence and it will show you the sentiment. Now see, this is the first sentence sentiment, second sentence, third sentence, and fourth sentence. Okay, I hope it is clear. But the model actually, it is using the default model. It is having only two label, which is nothing but positive and negative. But if you see this sentence, it is having some emotion. Okay, it is having some different sentiment. And if you want to capture different sentiments, you can use any other model. Let's say I will be using this model, Robota Base Go emotion model. So this can actually detect a multiple sentiment from a sentence. Okay, you can see all kinds of sentiment they have mentioned. See, these are the sentiment it is having. Okay, so that many of sentiment it can detect. Now let me use this model and let me again apply the same data. Now see, it will give you different sentiment. See, again, it is downloading the model. After that, it will do the sentiment analysis. Now the first sentence, it is admiration. Second one, confusion. Then amusement. Then anger. Okay, I hope you cleared. So I can say this is one of the very powerful library. Okay, if you want to work in the field of generative AI or natural language processing. Now you can also perform text generation task. So for this, in the pipeline, you have to mention text generation only. Okay, I think I showed you different tasks. Let's say I want to perform text generation right now. So text generation, I think it is there. Natural language processing, text generation. Okay. Now see, they have also mentioned in the tutorial, you have to give text generation in the pipeline. Okay. And you can also give the model. So the same thing I'm doing. Text generation model, I'm using Distilbert. And inside that I'm passing my input. Today is the rainy day in London. Now it will refer this sentence and it will generate the text. Okay. Based on this particular content. Now if I execute, see. See guys, beautifully it has generated the text. Today is rainy day in London, and one that no other city can remember or ever even know. A few days here ago, the police arrested. Okay, see, beautifully it has generated the text. Okay, so that's actually you can also perform text generation. Now if you want to perform question answering, just give question answering, and you have to give the question as well as the context. Okay, so based on the context, it will so by referring this context, it will give you the answer. Okay, let's say this is my question, what is my job? And here I'm giving the context. I'm developing an AI model with the Python. Okay. Now, if I give my question as well as the context, it will give me the answer. Again, you can check their documentation for the question answering. Question answering. So they're telling like that. So you have to give the question context and you have to pass to the pipeline. Okay, now see. Answer is developing AI model. That means this is my job. Okay, I hope it is clear. So I hope guys now it is clear how we can use this Hugging Face platform if I want to perform different tasks and how we can access different model. Now let's say you want to use large language model, that means LLM. So I think I showed you one amazing GitHub, Open LLM GitHub. So you can open this GitHub and you can see different large language model name. Let's say you want to use this model. Let's say you want to use this Falcon model. Falcon is a large language model. You can copy the name and simply you can go to the Hugging Face, go to the model section and simply search here. Okay, simply search here. Now see, Falcon model would be there. See, Falcon models is there. And Falcon is nothing but it's a large language model. It's not a language model. Okay, with the help of Falcon, actually we can perform different tasks. Even we can also perform chat operation. Not only that, all kinds of models are available. Let me show you. Let's say Llama 2. If you want to use Llama 2, I'll copy and I'll come here. I'll search for the Llama 2. See, Llama 2 is from Meta AI. Okay, like that we are having some another model also. Let's say Mistral is there. Then we are having something called Gemma. So this model is from Google side. So that's how we are having different large language model, and no need to worry. Going forward, we'll be using these are the model. But before using these are the model, we have to learn some additional, let's say, tools and technology. Like we'll be learning some generative AI framework like LlamaIndex, then Langchain. Then we'll be also learning about vector database. Okay, then we'll be learning these are the model as well. Fine. So yes, guys, this is all about from this video. I hope it is clear now. So in the next video, we'll be understanding about tokenizer, tokenizer inside actually Hugging Face. What exactly is tokenizer? Okay, and why we need it. Okay, why tokenization is required. So as I already told you, inside Hugging Face, actually, we're having another super important concept called tokenization. And now we'll try to understand why tokenization is important and why we use tokenization inside Hugging Face. I think you remember I taught you one concept called text preprocessing and text representation. So there, whenever I was passing any kinds of text to my model, first of all, I was doing the processing, then I was converting that particular text to the vector representation, right? And for this, I was using different technique. Like for text vectorization, I was using TF-IDF, word to vec, bag of word. Then that time, actually, I told you, we are also having some other technique, which is nothing but transformer based technique. Okay, because it is having something called attention mechanism. And then I taught you the attention mechanism concept, the transformer architecture. So there I showed you how it will give the attention to a specific word. Now it's time to show you this part as a practical. That means now we are using transformer based architecture, transformer based model, and whatever data actually we are passing as an input to my model. Okay. So internally, how it is processing that. Okay, internally, how it is processing that, internally, how it is converting to the vector representation. So it is using something called tokenization technique. Okay, tokenizer. So inside actually transformer, we are having something called auto tokenizer. Okay, so inside auto tokenizer, we have to first of all give the model name, like which model you have to use for that particular tokenization task. So to explain this tokenization, I just simplified this particular code. So first of all, I'm importing some of the necessary library I need. And here you can see I'm importing auto tokenizer. Okay, so let me import all the library. If you want to use any kinds of tokenization, so first of all, you have to define the model name, like which model you want to use. So here I'm using this model, BART-based multilingual unkissed sentiment model. So this model will, so with the help of this particular transformer based model, first of all, it will perform the tokenization. That means this input we are giving to the model right now, yes or no, right? So first of all, it will, this tokenizer, what this tokenizer will do, it will first of all pre-process. Let's say if it is having some HTML tags or any kinds of stuff word, it will try to remove. Then it will try to convert this text to the vector representation. Okay, then it will pass to the model and model will actually do the sentiment analysis. Now see if I execute the code. So first of all, it will download the tokenizer. Okay, then after downloading the tokenizer, it will also initialize the model. After that, it will do the sentiment analysis. So this is the high level understanding. Even I will also show you the low level, how it is generating the vector. Even we can also visualize the vector as well. See, now you can see this is the result we are getting. Fine. Now let's try to see how tokenizer is working. So if you want to use tokenizer, you have to import one library called auto tokenizer from transformer. The first thing what you have to do, you have to load one pre-train model. Okay, pre-train transformer based model. So here, let's say we are using BART based case model. So this is one of the transformer based model. Okay, you can see this is one of the transformer based model. So we're giving the model ID here. Then this is my example text. Let's say I'm giving into my tokenizer. Okay, so inside tokenizer, we're having another function called tokenize. Now after tokenize it, I'm just printing. Okay, after tokenizing, I'm just printing. Now let me show you what it will give me the output. So I can cut, these are the example. Now let me execute as of now. Now see, when you apply tokenizer.tokenize, it will give you the individual token. That means the tokenization we used to perform with the help of analytical library, I think you remember, right? Sentence level and word level tokenization. Now it is possible with the help of this tokenizer class only. Okay, that's why I told you transformer is like very powerful. So it's a high level wrapper. Inside that they have written all kinds of code. It will handle each and everything. You don't need to write any kinds of code from scratch. Okay, now if I want to convert this textual representation to the vector, what I have to do, I have to pass this particular token to the convert tokens to IDs, this particular method. Okay, and it is available inside tokenizer object. The tokenizer object we have defined here. Now it will give you the input IDs. Now let me show you this input IDs. I can take different cell and here I can execute. See, this is the input IDs, and this is nothing but your representation of the text. The text actually you have given. I was so not happy with the Barbie movie. Now you can see this is the vector representation of this particular text, and it is using transformer model. Okay, it is using transformer architecture in the backend, and it's like more powerful. Okay, it's like more powerful technique than your bag of word or TF-IDF or what to bake, whatever you have learned. Okay, and going forward we'll be using this particular approach only. Okay, I hope you cleared. But whenever I have to pass this particular vector to my model, I won't be using this particular method. For this you have to use this particular method. So here there is another function. So here you have to pass your data to the tokenizer. Okay, directly you have to pass to the tokenizer, and tokenizer will give you this output. Let me show you. See, this is the entire output, encoded input. Now see, input IDs, now it is familiar. So this is the input IDs. And here one additional token you can see, 101. What is 101? This is the start of the sentence. And start of the sentence represent 101. And end of the sentence represent 102. And in between actually you can see your entire vector. The vector actually you got. Okay. Now it is having another actually things called token type IDs. As of now, just try to skip this part, it's not required. And this is the important things, guys, attention mask. Okay, now I think you remember what is attention mask, that attention mechanism concept. That means whenever, let's say, it will pass this particular data to my model, in which word it will give the more attention. Okay, it is telling, now see, it is giving the attention to all the word, because every word is 1 you can see. That means this one will get the same attention, this one will give the same attention. Okay, this one will give the same attention. Okay, and how it is getting to know how to give the, let's say, attention, I think I showed you the calculation that I mean one calculation I was discussing in that JLMR blog. Okay, that's how it is calculating the score, and it is able to decide, okay, I have to give the attention to this particular specific word. Okay, I hope it is clear. So these are the actually output you will be getting after doing the tokenization. Now, if you want to decode the tokenization, that means if you want to again convert this, let's say, vector to text representation, you can use decode function for this. Now, I'll give my input ID. So whatever input ID I'm getting, I'll pass in the decode function, and decode will give me the previous text. Actually, you can see I was I was not happy with the Barbie movie. Okay, I hope it is clear now. Now, if I execute all of them all together, you can see this is the output. This is your tokens, this is input IDs, this is the encoded input, this is the decode output. That means this tokenization will first of all perform the pre-processing, then it will perform the tokenization, then it will convert your, let's say, text to vector representation. Okay, and additionally it will also give you some of the, let's say, number, which is nothing but attention mask. Okay, based on this attention mask, your model will decide in which word it has to give the let's say, attention more. So now I think, guys, this tokenizer is clear, like what is tokenizer exactly inside Hugging Face, because many people will have this question later on. That's why I just clarified right now, because going forward, whatever experiment we'll be doing, we'll be using the tokenizer, okay, from the Hugging Face itself. So for this, again, I kept one example. So here we'll be fine-tuning one dataset called IMDb, okay, IMDb movie review dataset, and we'll be using one language model, okay, from the Hugging Face itself. So for this here, we'll be using Hugging Face dataset only, because I already told you Hugging Face is having dataset, okay, dataset actually services. So you can also see different datasets, and this is the dataset count, guys, okay. Now you can search any kinds of dataset. Now let's say I want to use something called IMDb dataset. So IMDb. So this dataset is already available. See, this is the IMDb dataset, okay. So this is a movie reviews dataset. So here you have the movies, and based on that you have the reviews, okay, whether it's a negative or positive. So here we'll be fine tuning one text classification model. That means we'll be performing sentiment analysis. Okay, this is our main objective. So if you want to use actually Hugging Face dataset, for this you have to install one library called Dataset. Okay, so first of all try to install Dataset. And make sure you also install transformers. Okay, because I already installed transformers, so that's why I'm not going to install again. Now you have to restart the runtime. Now see, it is restarting the runtime. After that, we'll load the data. And loading data is very much easy. Only you just need to give the dataset name. Okay, so there is a load dataset function inside dataset. You have to call it, and inside that you have to pass the dataset name. It will automatically download the data from the Hugging Face. Okay, now see, this is the dataset name, IMDb. Just copy the name and give it here. Okay, it will automatically download. Now if I show you, so not only this data, you can use any kinds of data. Even I think you remember in the previous video I showed you that tokenizer. So in the tokenizer also you can take different model. Okay, different model for the tokenization. So there I was using BART-based case model. You can also use any other model. But remember, whatever actually model you are using for the tokenizer, the same model you have to use for the model training as well, for the model inference as well. Okay, this is the idea. Now let me show you. See, my dataset is downloaded. Now if you want to see the dataset metadata, so this is the dataset. Now we are having training data, text and labels we are having, and this is the example. That means 25,000 actually rows we are having inside training example, and test data we are having 25,000, and here we are also having unsupervised data. So here we'll be using this data only, train and test data. Okay, for my analysis. Now first of all, let's do the pre-processing task. So for this, I think you remember we have to perform the tokenizer. So here I'm importing auto tokenizer. So again I'm using this model, BART-based case model. Okay, so first of all, I will initialize my tokenizer. Then here I have created a function, tokenize function. Inside that, I'm just tokenizing my example. Now, which example I have to tokenize, guys? I think you remember, if I show you the data, let's say if I show you the first example, you can see this is the text. Okay, this is my reviews. Okay, this is my reviews, and this is the sentiment. So I have to apply on top of the reviews only. Okay, so that's why I'm giving text, example text, because inside example we are having the text. Okay, text keys actually you can see, because it's a dictionary format. Okay, that's the idea. And here I'm adding padding max length. Let's say, what is padding? I think remember. Let's say there is a sentence, this movie is good. Now let's say there is another sentence, I hate this. Okay, now just see the actually input length 1 2 3 4 1 2 3. So this input length actually having one word less. So in case actually what you can do, you can add some padding. Padding means 0 value. Okay, so that's why actually we are adding this particular parameter. Padding is equal to max length. That means first of all it will try to figure out the maximum length sentence. Based on that, it will decide what would be the padding size. Okay, this is the idea. Now here we are applying this particular function. You can see this tokenized function on top of my entire data set. Okay, and for this I'm using map function, and map will apply on top of the entire rows. Okay, this is the idea. Now if I execute, see this tokenizer will apply on top of my entire data set. Then I will get all of my vector. Now previously I only had this many of example. Now after tokenization, you will see you will have some more actually keys, like your attention mask. Then you will also get the input IDs. Okay, these are the things you will be also getting. So guys, as you can see, my tokenization is completed. Now if I show you my tokenized dataset right now, so see, now I am having all of the features like input IDs, token type IDs, and as well as the attention mask. Okay, everything. Now if I want to show you the data, how it will look like. So here you can visualize. Let's say I want to see my training data. Let's say I want to show you the first example. Now you can see the first example. This is the raw text. Okay, and after doing the tokenization, you got the input IDs, and input IDs is nothing but is the vector representation of the entire text. Okay, you can see this is the vector representation, and it will also have something called this one, attention mask. Let me show you. Token type IDs would be there as well as the attention mask. See, attention mask. Okay, I hope it is clear now. That means we have successfully converted our textual data to vector representation. Now we can start the training, but before that I have to first of all set some of the training argument, and transformer provides actually one function called training arguments. Okay, inside that you can mention training arguments. So these are the default actually arguments you can keep as of now. No need to change anything because again, it's a hyperparameter tuning. Only just change you can do number of epoch. Let's say how many epoch you want to train. Let's say I only want to train only, let's say, one epoch as of now. Okay, only one epoch I want to train. And output directory. So it will create a folder here called output directory. Inside that, it will save all the models and everything, right? Now let me set the training arguments. So again, this is kinds of template kinds of code. You don't need to remember anything. All the codes are available in the Hugging Face platform. So from there you can refer. Okay, you don't need to remember anything here. Fine. Now see, that many of actually training argument you can set here. Okay, after printing you can see. Okay, but I don't need to set all the training arguments. So we can only set these are the training argument. Fine. Now we can initialize the model. So here to initialize the model, first of all, you have to import to library auto. So here you have to import one library called auto model for sequence classification, because here we are doing text classification. For this, you have to use this particular class. Then you have to also import the trainer. Now, first of all, you have to load the model. You can see this is the model, part based case model. I'm loading. Okay, so if you give it here, it will automatically download. And number of labels I'm giving 2 because we are having only 2 labels, positive and negative. We are doing the sentiment analysis now of the IMDb dataset. And if you see the sentiment, only positive and negative. Fine. If you are having, let's say, 4 sentiment, that time you can give 4. Okay, I hope you're clear. Now simply we can initialize the trainer. Inside trainer, give the model, give the training arguments. Okay, the training arguments we are getting from here. This is the training arguments. Then we have to pass the train data. So this is my train data, tokenized data train. Okay, training sample. And evaluation data, I'm giving my testing data. Fine. Now let me click here. Now see, it will download the model and it will initialize all the trainer. Now see, training has not started yet because if you want to start the training, you have to call this particular things. Okay, trainer.train. Now see, if I click here, now it will start the training. And after training, it will save all the artifacts in the results folder. Okay, so it will take some time, guys. So let's wait. Once training is completed, I will come back. If you're using free Colab, so training will take some time. So you have to wait. Now, what you can do, you can also evaluate the model on top of the test data. So just try to execute this code. So again, it will take some time. Let's wait. After this execution, you will see the evaluation metrics. And in between, let me show you the training loss and validation loss you got after training. So this is the training loss and this is the validation loss in only one epoch. So here, if you increase the epoch size, you will see that this loss would be decreased. So try to increase the epoch size whenever you are training your actual model. As of now, I'm only training one epoch because I just wanted to show you. Okay, this is the idea. Now let's see the evaluation metrics. What is the evaluation metrics we get here? So guys, as you can see, this is your evaluation result. So this is the evaluation loss. This is the evaluation runtime. That means that many seconds actually took to execute this entire code. And you can see we only trained one epoch. Okay, so you just only need to see these losses, like how much loss you are getting. So this loss should be close to 0. If it is close to 0, that means your model is performing better that time. Now you can also save the model you have trained. You can also save the model. Even you can also save the tokenizer. Why you have to save the tokenizer? Because let's say in future user will come here and they will be using your model. So they will give some input, right? And input is what? It's a text. So again, you have to convert that particularly into the vector representation, yes or no, right? So to convert this input to the vector representation, I need to use my tokenizer, my train tokenizer, okay, not the previous tokenizer. Okay, that's the thing you have to remember. And as well as I also need to save my model. Now let me save both of them. Now you can see in the results folder, we are having all the checkpoints of our model training and all. I think you already know, if you have already learned previously, like how to train computer vision model, TensorFlow model, I think you know what is checkpoints. Okay, now see, we have successfully saved our model. Now if I refresh, now see, this model has been saved here. Now inside this folder, actually we are having different actually files. You can see config.json, then save tensors, okay, JSON. So this is how actually your Hugging Face save the model. Okay, it will contain actually multiple files. Inside config.json, you will have the entire configuration of the model. Okay, this is the main idea. So see, we have successfully saved our model as well as the tokenizer. Now let's see actually one project. Now let's try to do one small project. So here we'll be using this archive actually. So I think you know archive is a website. So here you will get different research paper. Okay, all kinds of research article you will get here. So first of all, we'll install this library because in Python we have this library. With the help of this library, we can actually download all kinds of article, right? We can get all kinds of article data. So now let me import. Now see, if you want to use this particular library archive, first of all, you have to prepare one query. You need AI or artificial intelligence or machine learning related, let's say, paper. Here you are giving the query. Now here you have to search. Okay, you have to search in the archive. Now here you can see I've given the query. Maximum result I need 10, and you have to pass this particular parameter called sorted by. Just try to mention submitted data as of now. Now it will give me different page, and I'm looking through the page and I'm extracting the published date, title, and abstraction and category of the paper. Okay, then whatever data I'm getting, I'm converting to the data frame and I'm just plotting it here. Now let me execute and let me show you. So guys, you can see I got the results. Now this is the published date, this is the title of the paper, and this is the abstraction of the paper. Okay, abstract of the paper, and this is the category. Now let's say I want to create a research paper summarization system. So what I can do in the pipeline, I can mention I want to perform summarization. Okay, and which things I want to summarize? I want to summarize this abstraction. Okay, this abstraction I got. You can see this is the abstraction column. Okay, abstract column. Now that's why I'm passing the abstract column from the data frame. And here I'm using this Facebook BART large CNN model. Okay, and inside that I'm passing my abstraction. Now see, it will give me the summary. So this model actually they train on the summary. Okay, summarization task. You can open it up and you can see the description of the model. They are doing the summarization task. Okay, so execution is completed. Now I got all of my summarization result. Now let's say I only want to see the first one. Okay, first summarization text. Now I can execute this code. You can also print all of them, it's up to you, but I'm only showing the first example. See, this is the summary of the first results. Okay, now, so I hope guys it is clear how we can perform the, let's say, fine-tuning operation on top of a pre-trained model. And no need to worry, going forward also we'll be exploring lots of model and we'll be doing the fine-tuning operation. We'll be implementing different application. Okay, on top of it we'll be implementing different projects. In this video I will show you how we can generate a Hugging Face API key, because I told you sometimes we need this API key. With the help of API key we'll be accessing the model. Okay, so for this we have to learn how we can generate a key. So as of now we'll be generating the key, later on we'll be using that. So for this definitely first of all you have to log in with your Hugging Face account. Now click on the profile icon. Now go to the settings. Now left hand side you will see one option called access key. Okay, access token. Now click here. Now see, previously I already created some of the access token, but for you it would be empty. Now if you want to create a new one, just click on create new token. Now you can give the token name. Let's say I will give my new token. Now you can give the permission. Now here you can provide the permission whether you want to create for the read access or whether you want to create for the write access. Okay, so let's say as of now I want to create for the read access. I only want to perform the read operation, and later on I will also show you how you can push your trained model to the Hugging Face hub. So that time actually you need the write access. Okay, so as of now let's create my token. This is your token. Just try to copy and save it somewhere. No need to share with anyone, otherwise they will also access your account. Okay, so it should be private. I will delete it after the recording, that's why I'm showing you. Now let me close it. So as of now I showed you the Hugging Face demo, like how we can use this Hugging Face platform, how we can access different model, even how we can also fine tune those are the model on top of our custom data. So in this video we'll be using the same technique and we'll be implementing one project called text summarization. Okay, so here is the notebook guys I already prepared. So the first thing what you have to do, first thing, just connect the notebook and make sure you change the runtime to the GPU, because here you need the GPU if you want to, let's say, implement this project, because here we'll be fine-tuning one transformer based model. Okay, we'll be fine-tuning one LM model here on top of our custom data. I'll tell you which model we're gonna fine-tune, even on top of which dataset actually we're going to fine-tune. But first of all, let me tell you what is text summarization. Text summarization means, let's say you are having a bigger paragraph and you are summarizing that particular paragraph. I think you know, okay, what is the summary, right? What is the text summarization project? So in internet actually you will be getting different summarization actually application. Let's say if I write text summarization online, so there are so many application you will see. This is another application from QLoRA actually. So here actually you can also give any kinds of text and it will give you the summary. So let me show you. If I search for English story, so what I can do, I can copy this text as of now as it is, and here let me paste it. Now if I click on summarize button, you will see that it will give me the summary of the entire text. Now you can also control like how much summary you need. So let's say I need a little bit bigger summary. Now if I again re-summarize, now see this result I'm getting, this is the actually a little bit long than our previous summary. Okay, so that's how actually we're having different application over the internet. So we'll be implementing this kinds of project, but here I'm not going to implement a user interface. User interface wise we'll be implementing later on. So as of now we'll be only doing the experiment on the Collab notebook. Okay, we'll be using transformer based model, we'll be using LM model, and we'll be doing this kinds of project. Okay, this is the main objective here. So let me get back to my Collab notebook, and first of all let me execute this command. So this command will show you which GPU actually you are using. So here I'm using Tesla T4 GPU because here I'm using free Google Colab. Now the first thing what you have to do, you have to install transformer library. Okay, why? Because here we'll be using Hugging Face actually platform, and to use Hugging Face platform I already showed you, you have to install transformer library. Apart from that, you need some additional package like sentence pieces. Okay, then you need Scareblue, then RowScore, okay, and Pi7Zr and datasets. Why dataset? Because with the help of datasets we'll be downloading the dataset from the Hugging Face itself. Okay, that is why. And these are the dependency packages you also need to install here. Fine, so let me install all the packages one by one. So my installation is completed. So the next thing what you have to do, you have to update some of the packages. The first package you have to update called Accelerate. Then you have to uninstall your older version of transformer and Accelerate, and you have to install the latest one, because what happens actually in Google Colab, sometimes they're using older version of the transformer package and Accelerate package. Okay, so that's why I'm updating it again. Okay, that's the things you have to do. And what is Accelerate? See, Accelerate will help you actually to access your GPU. That means here you are using GPU, you are using something called CUDA. Okay, so to use your CUDA actually instance, this Accelerate will help you. So whenever it will do the fine-tune operation, that time actually it will access your GPU, right? So that's why actually this package is required. Now let me update all of them. So as you can see, update is successful. There is no error. That means everything is working fine. Now the next thing, you have to import some of the necessary library to test whether everything is working fine or not. So here you can see I'm importing pipeline. Then I'm also importing load dataset from the dataset. Okay. And apart from that, I'm also importing some additional library. Okay, some extra library also I'm importing here. It is not required, but what the library actually I'm going to use like later on I'll tell you, okay, why I'm using that one. So as of now, let me import all of them. See, this execution is fine. That means there is no error. We have successfully installed all the packages. Now I think I already imported Torch, so I don't need to import this line. I can delete. Now the first thing what I have to do, I have to check the device, okay, whether it is utilizing my CUDA or whether it is utilizing my CPU. So as I already showed you, I have changed my runtime to the GPU, right? And here you can see it is connected with my T4 GPU. That means it should use my CUDA. So let me check. See, it is utilizing my CUDA. So here I'm using Torch, PyTorch library to check it whether CUDA is available or not. If yes, print CUDA, otherwise print CPU. So you don't need to manually set your machine type. So if you have the like GPU installed in your system, and if all the tools and let's say services are already installed, so it will utilize that particular GPU, that means your CUDA. Otherwise it will automatically utilize your CPU. Okay, so if you see any kinds of PyTorch implementation, PyTorch use this particular code snippet, okay, to map with your CUDA or with your CPU. I hope it is clear. Now the first thing what I have to do, I have to load my tokenizer. Okay, tokenizer. And what is tokenizer? I already explained. With the help of tokenizer, we'll be preprocessing our data, and I will be converting my text to vector representation. So for this, I'm going to import auto tokenizer from transformer library, and another class I have imported auto model for sequence to sequence LM, because here we'll be loading one LM model. That means we'll be loading one transformer based model, and to load the transformer based model, actually you have to use this particular class. Fine. Now let me import this package. Now here is the model checkpoint, guys. So here we'll be using one model called Google Pegasus CNN Daily Mail. Okay, so this is the transformer based pre-train model, and this is the model, guys. This is from Google. So Google has trained this model, and this model can perform text summarization. Okay, now if you want to test it, here is the inference API. Now here you can see it will give you the summary. Okay, summary of the entire text. Now you can see like what kinds of data set they use to train this model. Every information they have given, okay, about the model. So if you're interested to deep dive, you can check this documentation. You can check this model cut. You will see each and every details. Now if you want to see the model, just click on files and version. You will see the GB of the model. it is around 2.28 GB, and there is another file, it is around 3 GB. Okay, so total I think 5 to 6 GB this particular model. So whenever I will download this model, you will see that, okay, what is the model size as of now. Let's get back. So now let's load the tokenizer, and I already told you the model actually will be using the same model you have to use for the tokenization as well. Fine, this is the idea. Now let me load the tokenizer. So for this, I'm using auto tokenizer from Pretrain, and here I'm giving the model checkpoint. It will automatically download from the Hugging Face itself. So fine, I have already downloaded the tokenizer. Now we'll be downloading the model. Okay, so to download the model, I'll be using this class auto model for sequence to sequence LM, this class, and there is a function called from Pretrain. You have to give the model checkpoint and to device, like in which device you want to load the model. I want to load the model inside my GPU. Okay, that's why I'm giving GPU to device is equal to my device. Now let me load it. Okay, my model has also loaded. Now we'll be loading the dataset, and dataset wise we'll be using one dataset named Samsung dataset. So this is the dataset, guys. So this dataset is from Samsung actually. So they have published this data. And the Samsung data is nothing but it's a dataset containing about 16K messenger like conversation with summaries. That means it is having actually different conversation. Okay, and in the another column actually it is having the summaries, okay, of that particular, let's say, conversation. So if I show you, let's say this is the conversation. Okay, this side you are having the conversation, and this side you are having the summary. So let's say this is the conversation, and this is the summary. Okay, again this is the conversation, this is the summary. So that's how they have collected the entire data, and it is having 16K actually messenger like conversation data. Fine, and the dataset name is Samsung data. And if you want to see the dataset is split, so it is having around 14,732 example for the training, validation that many example, and testing that many example. Fine. So again you can see this documentation if you want to learn more about this data. Now let's download the data. So for this I'll be using load dataset from my dataset package. Now let me download the data as well. Now I'll give yes and I'll press enter. It should download the data. Okay, now if I show you the dataset metadata. So this is the metadata, guys. So as I already told you, it is having a dialogue and summary, and that many of example you are having for the training, testing, and validation. Fine. Now if you want to see any kinds of, let's say, dialogue, that means your entire, let's say, conversation, you can also visualize. So let me visualize one of the example. So this is the dialogue, guys. You can see Olivia is telling who are you voting for this election. Then Olivia is saying liberal as well, and Olivia, me too. Olivia, great. Okay, so this kinds of conversation it is having, and based on that it is having one summary. So let me also show you the summary. So I'm printing the summary here. You can see, so Olivia and Oliver are voting for the liberals in this election. Okay, so this kinds of actually data set they have prepared. Now this particular code snippet will print the number of example you are having in this data set, as well as the split length and the, let's say, entire dialogue and entire summary. Now let me show you. See, this is the split length, this is the training, validation, and testing, and these are the features it is having, like ID, dialogue, and summary. And this is the entire dialogue you can see. Okay, and this is the summary of the dialogue. So this is the preview of the data. That's why I just printed. I just wanted to show you, okay, what kinds of data they collected. Now let's say you are having some different kinds of data. So what you can do, you can give your, let's say, entire, let's say, paragraph as a dialogue and the summary as a summary. Okay, and you can follow the same approach. Okay, it doesn't matter. Now the next thing what I have to do, guys, I think you remember, I have to pre-process my data and convert to the vector representation. So for this, what I have to use my tokenizer. Okay, I think you know. And on top of which actually, let's say, column I have to apply my tokenizer on that dialogue, because dialogue is my actually paragraph. And again, if you see the summary is also a text. Okay, so I also need to apply the tokenizer on top of the summary as well. So here I've written a function convert example to features. So it will take the example batches, that means your dialogue and summary, and it will perform the tokenization operation. You can see. So first of all, I'm applying tokenization on top of my dialogue. Then I'm applying tokenization on top of my summary. Then whatever results actually I'm getting, I'm just returning. That means you will get input IDs, attention mask, as well as the labels. I think I showed you. Okay, from that example. Now let me execute. And now let me map this function on top of my entire data set. Okay, so see here I'm doing the map operation. Now first of all, let me convert to vectorization, then I'll show you, okay, how it will look like. So see, execution is done. Now if I show you my data set right now, see it is having different features: ID, dialog, summary, input IDs, attention mask, and labels. Okay, because I converted to the vector representation right now. Now if you want to see the input IDs, so this is nothing but your input IDs. That means this is the vector representation of the first dialog. Okay, and if you want to see the attention mask, you can also print the attention mask. So this is the attention mask. That means it is giving all the word as the same attention. I already explained this part. Fine. And if you want to print the label as well, that means the summary, you can also print it. Let me show you. So here I will print the labels. So this is the labels. Okay, that means this is the summary of this dialog. Fine. I hope it is clear. Now we'll start the training, but before that, what I have to do, I have to set some training arguments. I think you remember, right? But before that, one thing you have to do, if you're using a large amount of data, so you have to initiate this data collator. Okay, so what data collator will do? Data collator will help you to load your data as a batches in the memory. See, here you are having so many examples I showed you na, in the training, validation, and testing. So I don't need to load the entire data in my memory, because here if you see my memory size, I got actually 12 GB RAM. So if you're having huge amount of data, so 12 GB RAM is not enough. So for this, what you can do, you can load your data as a batches. That means some amount of data will be loading. You will be training again. You'll be taking another batches again. You will be training. That's how you can perform the operation. So this data collator will help you to load your data as a batches. And if you want to define the data collator, you have to use this class from transformer, data collator for sequence to sequence. So here you can see I'm passing my tokenizer and model inside the data collator. Fine. Then you have to initialize this data collator object. So let me initialize it right now. Now the same thing, you have to set the training arguments. So as I already told you, just keep all the arguments as same. No need to change anything. Only you can change the number of epoch. Okay, you will be training. So as of now, I'll be showing you only one epoch training because again, it will take time. We are using free Google Colab. Okay, and the output directory I want to create Pegasus Samsung. Okay, so it will create our output directory Pegasus Samsung. Inside that, it will save all the artifacts. Fine. So let me initialize the argument as well. Then I will initialize my trainer object. So it will take the model, your training argument, tokenizer, data collator, and you have to pass the training data. Now see here, one small hack actually I'm doing. See, if you see the training data size, it's very huge. So as I already showed you here. So that many training example, it is having almost 15,000. So if I'm taking 15,000 data for the training, it will take lots of time. And this is my validation and testing. So what I'm doing actually, instead of taking the training data, I used actually test data as my training data, because inside test data I'm having very less example, so that I want to show you the quick training. But if you are training actually, okay, if you are doing the actual training, that time you just use train data, okay, not the test data. So this is the hack, guys, small hack I'm doing, because if you want to experiment something and you don't have that much of time, so you can take a small amount of data and you can perform the let's experiment. Okay, so that is what actually you can perform. And here you can see evaluation data. I'm giving my validation data. It's completely fine. Okay, now let me initialize my trainer. Now if you want to start the training, you have to call trainer.train. Now it will start the training of the model. So it will take some time. So I will pause the video, and once training is completed, I'll come back. Okay, so my training is completed. Now here you can see my training losses and different metrics that it is giving, but you have to check the training losses. So this loss should be close to 0, guys. Okay, if it is close to 0, that means your model is performing well. Now if you want to evaluate this model on top of the test data, you have to use this function, calculate metrics on test DS. Okay, so here you will be calculating something called row score. Okay, what is row score? See, row score is a metrics for the summarization model. Take summarization model. You can search on Google. You will find the row score actually equation. But as of now, I won't suggest, don't deep dive into the equation. Just try to consider it just a evaluation metrics. Like for the classification, actually what evaluation metrics we used to use, like accuracy score. Then we used to use confusion metrics, AOC curve, right? And here we are performing something called text summarization, and text summarization uses one metric called row score if you want to evaluate that model. So similar wise, for language translation, we use another kinds of metrics. For let's say name entity recognition, we use another kinds of metrics. For let's say Conversational agents, we use another kinds of metrics. Okay, all kinds of tasks is having their different evaluation metrics. Okay, this is the main idea here. Now before that, let me show you the models actually it has trained. Now inside Pegasus Samsung folder, this is the checkpoints. Inside that you can see this is the model actually it has trained. Now we'll be saving this model as well. So just let me first of all show you the evaluation metrics, then I will say tell you how we can save the model. And now you can ask me where I got this function. See, if you just go to the Hugging Face, that documentation, go to the text summarization task, you will see that they're suggesting this function. Okay, so they're suggesting if you want to perform the evaluation on top of the, let's say, your text summarization model, you can use this row score function. Okay, this is the idea. Now here we'll be calculating our row score. So here you are having actually 4 kinds of row, like row 1, row 2, row large, and row L sum. Okay, now let me calculate the row score. First of all, I will be loading all the row matrices. I have to give yes. Then I will be calculating the score on top of my testing data. Okay, now let me execute. And again, I'm only taking 10 example, guys, because it is having actually lots of data and it will take time. That's why I have taken only 10 example. But if you are performing actually, so but you can remove this line. That means you are performing on top of the entire data right now. Fine. This is the small hack you can follow if you're doing the experiment only. Now see guys, this is my row score I got. Now guys, you can see I got the row score, and this row score should be close to 1. Okay, if it is close to 1, that means your model is performing better. So as of now, we used our test data for the training and we only trained one epoch. That's why this row score is not good. Okay, but if you're using actual training data and if you train multiple epochs, you will see that you will get a good row score here. Fine. Now let's save the model, my Pegasus model. So I'm using save pretrain function. And here I'm giving the names, it will save my model. So now if I refresh, you can see my model has saved. So this is my model, Pegasus model, my trained Pegasus model. Then I also need to save my tokenizer. Because later on I will be giving my, let's say, testing data. And if I want to do the, let's say, summarization task, that time it will also convert that data to the vector representation. Now see, this is my tokenizer. I also save, fine. Now, if you want to load any kinds of pretrain tokenizer, what you can do, you can use auto tokenizer from pretrain. Now you can give your tokenizer location. Okay, now see here I'm giving my tokenizer location, not the tokenizer we downloaded from the Hugging Face. Okay, now let me load my tokenizer. So this is my custom tokenizer right now. Now this is the prediction code. Okay, now to perform the prediction, first of all, you have to generate some arguments. Now you have to set the length penalty, then number of beams, then max length. So you don't need to change this parameter, just keep it as it is. Only you can change this length penalty. What is length penalty? I think you remember. So here we had one, let's say, interface, like we can generate short output, we can generate long output. Now if this parameter is close to 1, that means it will generate actually long output. If it is close to, let's say, 0, it will generate short output. Okay, this is the idea. Now here you can see I'm taking a sample text from my test data. I'm taking actually dialog 1, the first dialog. Okay, you can see from the testing data I'm picking up the first dialog. Let me show you. So if I execute it here, so this is the first dialog I'm taking from my test data, and I'm also taking the reference, that means the actual summary of it, because I want to match this summary with my actual prediction of my model. This is the actual summary, right? Then what I'm doing, I'm creating a pipeline. I think you know what is pipeline in Hugging Face, and here I'm telling I want to perform summarization right now. And I want to use my model, the model I trained. So this is the model I trained. I'm giving the name of the model. You can see, okay, Pegasus Samsung model. And here I am passing my tokenizer. The tokenizer actually I loaded here. Fine. Then I'm creating the pipeline. Now here I'm printing my sample text. That means the text actually we have loaded this first dialog as well as the reference. That means my actual summary. Then I'm predicting my model. You can see I'm passing this sample text to my pipe object. Okay, my pipeline, and here I'm giving all the parameter I set here. Okay, then whatever output I'm getting, I'm only printing the summary text of it. Now let me show you. If I execute this code, see, this is my actual dialog, this is my actual summary. Now my model is predicting, okay, the prediction summary. Let's wait and let's try to match, okay, how much accurate it is. Now see guys, I got the prediction. Now just try to see. Now you can see this is the model summary. That means my model has given me the summary. Now see, it's not very accurate, but still it is close to, because again I told you we only trained one epoch and we used our testing data for the training. Okay, that is why it is actually not, it is not giving actually good performance. Okay, and if you want to increase the performance, what you can do, you can increase the epoch size and you can test, and you have to train on top of the training data. Okay, not on top of the test data. Okay, this is the small modification you can apply. So I hope guys it makes sense right now how we can actually implement different projects with the help of Hugging Face platform now. Okay, that means I showed you how we can use different model, whether it can be LM model, whether it can be LLM model, how we can use different data sets. Okay, and how we can use the Hugging Face pipeline, okay, to create your application. So this was my main objective, the proper use of Hugging Face. Okay, because going forward we'll be utilizing this particular, let's say, technique only to perform all of the, let's say, project. Okay, whatever project we'll be doing, we'll be following this particular approach only. And going forward, I will be also showing you how we can use large language models. So see, now we are using LM model only, okay, language model only. But going forward, we'll be using large language model. That means we'll be using Llama model. Okay, we'll be using Llama model from Meta. We'll be using, let's say, Mistral model. Okay, we'll be using Falcon model. Different like large language model will be exploring. Okay. So I hope guys this is clear now how we can perform this text summarization project. Now one task I want to give you, see, I already told you now we are having different data sets in the Hugging Face. So you can select based on the task. Let's say if I go to the task, let's say I want to perform summarization. I'll click the summarization. Now see, these are the data related summarization. Now what you can do, you can pick up any kinds of data set from here. Okay, and you can perform that text summarization on top of the data. See, here I used Samsung data, but I want you to use some any other data. Okay, so please try to attempt this task, because unless and until you are not doing like a practical from your side, it would be a little bit difficult for you. So if you want to actually generate image from the text, so you have to use something called diffusion model. Okay, diffusion model. And what is diffusion model? Diffusion model is kinds of actually large language model. It is available in the Hugging Face. Okay, and if you want to use diffusion model, you have to use one library called diffuser. Okay, diffuser. So this diffuser will help you to actually load these kinds of diffusion model, and you can perform these kinds of text to image generation. So again, it is available inside Hugging Face only. So you don't need to go to the any other platform. Okay. So additionally, we just need to install another library called diffuser, and with the help of that, we can easily access that diffusion model. As of now, I don't need the Gradio here. I can remove it. So these are the library actually I have to install here. So as you can see, diffuser is the Hugging Face page for using the diffusion model from the Hugging Face hub. So here you can see, let me show you the page. Actually, I have already given the link. So see, this diffusers is available inside Hugging Face only. So they have already written like how we can install it, okay, and how we can load the diffusion model and all. Every example they have already given here. Fine. So I have followed this documentation, guys, and I prepared one notebook for you. And let me show you how we can perform this text to image generation with the help of different large language model. And here the model actually will be using, guys, this is actually multi-model. That means this model uses both kinds of architecture, your NLP architecture as well as the computer vision architecture, because here you have to give the prompt. That means text is nothing but your prompt, okay, and it will generate the image. That means first of all it will process the text, then it will process that particular image, okay, image output. So that's why it is using something called hybrid architecture. Okay, so it is called actually multi-model. I hope you clear. Now let me install all required package I need here. Now let me import this stable diffusion pipeline for diffusers. The same way actually we used to load our pipeline. I think you remember from the transformer. So here also we have to load the pipeline for the diffusers. Okay. Now I also need the matplotlib because I want to visualize the image. Then I also need the torch library. Now if you want to see the version of any package, you can execute this command pip show the package name. It will show you the version. Okay. Now here I kept actually two kinds of diffusion model. This is the model ID 1 and this is the model ID 2. You can see the first model. This is the first model. So the model name is Dreamlike Diffusion 1.0. So this is the model, guys, and it is available in the Hugging Face hub. Okay. See, whatever models actually you can see in the model section, this is called actually Hugging Face hub. That means in the hub also you can upload your own model. It is possible. Let's say if I click on the model now. So inside this model, you can upload your own model. Let's say you fine-tuned one model and you want to share with the community. You can also push your model here. Okay, so the other people can download your model and they can use it. Okay, I will also tell you how you can push your model to the Hugging Face hub. everything I'll try to show you. Even you can also upload your own data set. Okay, it is also possible here. Now this is the model, guys. You can read about the model, and this is the a few results. Actually, you can see they have given different prompts, and these are the results they have generated. Okay, this is one of the amazing model. Even they have also given the code snippet, how you can use it and all, everything they have given. Now another model, actually, this one, the model name is Stable Diffusions Excel Base 1.0. This is the model. So this is the model architecture, high level architecture. That means first of all you have to give the prompt, and with the help of actually transformer model, what they will do, they will just try to understand this prompt, and they'll try to perform the tokenization, convert to the vector representation. Okay, that means converting to the embedding. Then they'll be creating one latent dimension 120x cross 120x, and this latent dimension will pass to the unit model. If you don't know, inside distributable diffusion, actually unit model is used. So unit model will try to generate the image, okay, with respect to the prompt user has given. Okay, you can see last I'm getting the image output. Again, they have already given the paper link and all. If you're interested, you can open it up and you can learn. Okay, see, they have also given the code example. Now let me show you how we can use this model. So what I've done, guys, I'm loading the first model. You can see stable diffusion pipeline from Pretrain. I'm loading the first model, and here you have to give some parameter. Okay, that means torch data type torch.float64, and use safe tensor is equal to 2. Okay, you have to pass this to parameter. Now I'm loading this model inside my CUDA. That means inside my GPU, because if you load inside your CPU, it will take lots of time, right? So that's why I'm loading everything inside my GPU. Now let me show you. See, it is downloading the model. Now here I have prepared one prompt, guys. You can see this prompt: dreamlike art, a grungy woman with rainbow hair, traveling between dimensions, dynamic poses, happy soft eyes and narrow chin, extreme bouquet, tiny figure, long hair straight down and tone, quali shirt and baggy jeans. Okay, so this is my prompt actually I have prepared. Now you can give any kinds of prompt. If you feel like, okay, you have to use this prompt, you can give it here. Now this prompt actually I have to give my pipeline object. That means inside my model, and model will give me the image matrix. Okay, so let me show you. So it is generating this image right now. I think currently in the ChatGPT also it is having one model called GPT 4.0. Okay, so this model also can generate actually different image. So see, create an image for my presentation. Now if I click here, now see, it is utilizing something called GPT 4.0. See, if I click here, see, GPT 4.0 they are using. Now it is asking, just try to give any kinds of prompt. Let's say if I give same prompt here, let's see what happens. See, it is generating the image right now. So they are also using this kinds of diffusion model in the backend, multi-model. That means they are understanding the prompt, then they're generating the image. Okay. See, okay, this is the output I got. Now let's see from my model, actually, the model actually I'm referring from the Hugging Face. See, if I plot this image right now, you can see this is the results I got. Now see the ChatGPT and see my results. Both are pretty good. Now you can also plot with the help of matplotlib. It is also possible. First of all, I'm printing the prompt, then I'm printing the image. Okay. Now let me give another prompt. A girl is sitting on a chair and she is accompanied by her tiger. Make sure to keep it cinematic and color to be golden IDs. Okay. Now let me see the output. The same prompt you can give to the ChatGPT as well. Let's see. So here I think I got the results. Now let me plot the image. See, this is the image I got, and see, this is the image I got from my ChatGPT. So both are good, guys. Now I think you got it, how we can use these kinds of actually multi-model as well. Okay, if I want to, let's say, generate text to image or image to text, okay, everything is possible. Now if I show you, so if you just go to the Hugging Face model section, here, if you click on the model, now see, here you are having different tasks. Let's say you want to perform text to image generation. So here is the task, guys. Inside computer vision, you can select it. Now see, you are having different model. So here I was using diffusion model. You can also use any other model. Okay, see, that many of models are available, around 34,000 model. You can use any of the model. Okay, any of the model, and you can try. So this should be your task, guys. I will leave it to you. You can export any kinds of model from the hub itself. Okay, only select this task, text to image. Okay, now let's see if you want to perform image to text, that time select this one, and you can see the different model. Even if you want to see the example, open it up. They have also given the lots of example here. Okay, code snippet, everything they have given, you can learn from here. So this is the best platform, guys, if you want to deep dive inside Hugging Face. Fine. Now we'll be learning some parameters of the diffusion model. Like you can set some of the parameter. Okay, let's say you want actually different dimensional image. You want to, let's say, add some more parameter in that image. You can also do it. For this, I created a function generate image. So it will take the pipeline object prompt as well as the parameter, and whatever things actually you will be assigning the parameter, it will set inside pipeline, and it will render the image with the help of matplotlib. So let me execute. See, that many of actually parameter you can play with: negative prompting, and now num inference step, height, weight. Okay, number of image per prompt. Okay, now let's say this is another prompt I have prepared. As of now, parameter I am not giving anything, it's empty. Now if I pass these are the thing inside my generate function, so it will give me the image. So this is the prompt: dreamlike beautiful girl playing the festival of color, wrapped in traditional Indian attire, throwing colors. Okay, this is my prompt. Now you can see based on the prompt, it has given me one beautiful image. Okay, see, beautiful image it has generated. Now I can give any kinds of prompt. Let's say number of inference step, I have given 100. Now let's see what kinds of input I get. You can see the documentation of the this one diffusers. You will see different actually parameter we're having there. See, this is another example. Now you can see both images are same. I can't see any difference. Now let's see with any other actually parameter. Let's say height. I want to change actually different height, height and weight. So for this, you can pass this height and weight parameter here. Now let me see. So now you can see, guys, I got the results and in a different height and width right now. So that's how you can play with different parameter. Now let's see another parameter, number per image prompt. That means if I want to, let's say, generate multiple images, that time I can give image number of images per prompt 2. That means it will give me 2 images right now. So here is the results. Now I am getting 2 output from my image. Now let's say you want to get 3, you can give 3 here. Now let's also see the negative prompting. So here I have added negative prompt: ugly, destroyed, and low quality. Let's say this is my negative prompt. Now let's see whether it is able to generate or not. So right now you can see these results and these results. I think you can see the difference. This is a little bit low quality, and the prompt I have given ugly, destroyed, and low quality. So it is almost matching, I think. Fine. So yes, that's how we can use this kinds of multi-model, and I can do the text to image generation. Fine. Now I already showed you we are having so many model, guys. Just try to explore from your end some of the model and try to implement any kinds of projects. Fine. So guys, so far what we have learned. So we saw how we can use the existing model from the Hugging Face. That means, let's say if you want to use any pre-train model, you can directly use it. So you have to use something called pipeline. Okay, pipeline. For this, inside pipeline you have to mention the task you want to perform. Okay, let's say you want to perform sentiment analysis, you want to perform, let's say, translation, you want to perform, let's say, summarization, you can mention. Or else what you can do, you can also do the fine-tuning operation. Okay, fine-tuning of a pre-trained model. Okay, and I already showed you one fine-tuning example, like I did the text summarization. Okay, text summarization. So there I trained on top of my custom data. Now you can ask me when we have to use pre-trained model and when we have to do the fine-tuning operation. So let's say whenever you are having a problem statement, let's say you want to do text summarization only, Okay, text summarization only. First of all, try to use the existing model. That means the pre-trained model. Okay, pre-trained model. Let's say I showed you one model, Google Pegasus, that CNN Daily Mail model. Try to use that model and try to see whether your model is able to give the correct, let's say, summary or not. Correct summary or not. If it is able to give the correct summary, then why you need to do the fine-tuning? Definitely not. You can use this model as it is, right? But let's say if your data is a little bit different, let's say you are using something called, let's say, banking data. Okay, banking data, banking related, let's say, conversation you are having. And this conversation is not working with that pre-trained model. That time what you can do, you can collect your own data, that means your custom data, okay, custom data, and based on that you can fine tune one, okay, fine tune one pre-trained model. That means you are using one pre-trained model, on top of that you are adding some more knowledge, then this model will be able to also work with the banking data as well. This is the idea only. Okay, now I think you got it, when you have to use the pre-trained model and when you have to do the fine-tuning operation. It can be for all kinds of, let's say, model. It can be for the multi-model, it can be for the let's say LLM model, it can be for the LM model, any kinds of model actually it can be applied. Okay, so the model I showed you now right now, this diffusion model, this text image generation model, let's say if it is not able to generate the image the way actually you are giving the prompt, that time what you can do, you can fine tune this model. It is also possible you can also fine tune the diffusion model. And how to fine tune? Again, they have given all the, let's say, article here, fine tuning everything they have given. If you just go to their documentation, you will easily learn. Even I will also show you in future, okay, how we can do the fine tuning of the large language model. For this, we'll be using another technique called PEFT. Okay, that means parameter efficient fine tuning. What is PEFT? I will tell you. Parameter efficient fine tuning, because what happens, these kinds of large language model is very huge, and I can't train this kinds of model actually on my this kinds of machine, the Google Colab actually I'm taking, because it's a huge model, huge parameter. For this we have to follow this parameter efficient fine tuning process. Okay, that time I'll discuss what is the use of that and how we can fine tune those example and all. Okay, everything I'll try to clarify. As of now, I'm only the exploring like the service actually it is having, so that you can get familiar with, okay, that are the things actually we can perform with this particular platform. Like how we can do text to speech generation with the LLM, okay, with the help of this Hugging Face platform. So again, I have to install this transformer library, because inside that only I am having all the, let's say if I search for Hugging Face, so if I go to the model section, so now let's say we'll be working with the audios, that means text to speech. Now if I click on text to speech, see it is having actually different model, okay, different model actually it is having. But the model actually I'm going to use this model called Suno Bark small model. So this is one of the transformer based text to audio model created by Suno. Okay, now if you want to read about this, you can go ahead and try to read about this particular model. Even they have also given the example, even though they have also given the Colab notebook, how we can use it. See, this is the Colab notebook they have given. But so many things they have written, so what I have done, I just simplified this notebook, and this notebook I created. Okay, now let me show you how we can perform the text to speech generation. Now for this, first of all, I have to import that pipeline from the transformer, and here is the text, guys. So this text actually I'll be converting to the audio. Now see, Python is a high level general purpose programming language. This is my text. Now in the pipeline, I want to perform text to speech, I have to give, and I have to give the model. So here I'm giving my model ID. This is my model ID, Bark small model. Then device is equal to CUDA, because I want to load my model inside my GPU. Now it will give you the output, and output would be a NumPy array. So let me show you. If I just execute this program, see, now if I print the output would be a NumPy array. Okay, now I have to convert this NumPy array to audio, that is audio frequency. For this I'll be using one library, IPython display audio. This library will be using, and I have to give this array as well as the sampling rate. Okay, so here you can see I'm passing my audio, that means this array, as well as the sampling rate. Now if I execute, it will automatically convert this array to the audio. Now see, if I play,
Python is a high-level general purpose programming language.
See, I think you heard of, okay, it is speaking that particular text. Now you can give any kinds of text, it will generate the speech for that. Fine. Now you can play with different model, guys. I already showed you it is having different model. You can try with different model. Okay. See, I was using this model, Bark small model. You can also use any other model. Okay, it's up to you. So that's how, guys, you can explore this Hugging Face. It's an amazing platform, and it's like very powerful platform, guys, in the field of generative AI or in the field of natural language processing. If you don't know about OpenAI, OpenAI is a platform for the generative AI. So with the help of OpenAI, you can implement any kinds of generative AI application. OpenAI provides lots of commercial large language model like GPT series. I think you already used Hugging Face, right? So this is the similar kinds of platform of the Hugging Face. So Hugging Face provides all the model, all the data set as free. but OpenAI provides actually everything as a paid. That means you have to take their subscription. So if you're taking their subscription, that time actually you can use their premium model. Apart from that, OpenAI provides some of the model for the free access, so that at least you can do some experiment, okay, with this model. But if you want to build let's say production grade application, that time they are suggesting to take their premium model. So guys, through couple of video we'll be learning about this OpenAI and its platform. So here we'll be learning all the services from the OpenAI, how we can use the entire OpenAI platform. So everything I'll show you here, how we can generate OpenAI API key, how we can access like different model, okay, and how we can implement different applications. So let's open our OpenAI platform. So guys, if you want to open this OpenAI platform, just search for OpenAI login. So you'll get the first website, OpenAI platform. So make sure you have one account. If you don't have an account, you have to first of all create one account. And whenever you are creating an account, it will ask for your card. So try to add your card. So you will get initially actually $5 credit here. Okay. I think $5 credit you will get. Then once you use that $5 credits, then what you have to do, you have to pay for the services. Okay. Whatever services you will be using, whatever model you will be accessing. So based on that, you have to pay. Now you can ask me how much, let's say, money it will take. Okay. I'll tell you how much money actually it will charge. It will charge based on the token size. As of now, just try to see the overview of this OpenAI. Then I'll tell you each and everything. So here you can see guys, after login, I'm getting two windows. One is like ChatGPT and this is like API. See, ChatGPT is also product of OpenAI. I think you already know, right? So this is my ChatGPT and this is the product of OpenAI. That means it is using GPT model. You can see if I click here, it is using GPT model. Okay, GPT model. So GPT has like different model variant, like GPT-3 is there, 3.5 is there, 4 is there. Even recently one model has published GPT-4o, and this is another like powerful model they have published. Apart from that, it is also having some multi-model, like it can generate text to image, like DALL-E model is also there, right? Then it can also, let's say, generate like text from an audio. That means a Whishper model they are using. So it is having actually different model. I'll tell you what are the model it is available. So first of all, click on the API part. So now see, this is the API interface, but as of now, I'll go to the playground. See, this is the playground. That means if you're opening this OpenAI for the first time, so what you can do, you can test different model here, you can see. But again, I'm telling you guys, you have to first of all create your account and make sure this $5 is let's say credited in your, let's say, account. Okay, otherwise you won't be able to use this playground. Okay, that means you won't be able to access these are the model. So make sure your account is active. Okay, then after that you will be using. So whatever, let's say, chat operation usually perform with the ChatGPT, the same thing you can perform here. Okay, so here you can select different model you can see. So by default it is GPT 3.5 turbo. You can also take GPT 4o mini, GPT 3.5 turbo 16K. Okay, that's how different model it is available. Okay, so here you can give the prompt and here you can pass the system instruction. So I'll tell you about that, what is system instruction. So whenever, let's say, we are using GPT model, we are having two kinds of, let's say, API. The ChatCompletion API, another is like the completion API. Okay, so both has the difference, I'll tell you. Now here you can also perform the assistant related task. Let's say if you want to create your own assistant, okay, you can also use this service. You can also do the text to speech generation, okay, with the help of this OpenAI. You can also perform the completion operation. That means sentence completion operation. So you can write one sentence, it will complete the entire sentence or let's say entire story. Okay, so all kinds of model it is available. Even it is also having DALL-E model. Apart from that, actually they are also having something called DALL-E model. DALL-E is a text to image generation model. If you are giving any kinds of prompt, it will generate image for you. Nowadays in the ChatGPT also they integrated this functionality. Let me show you. So this is what I will select, create an image. Now it is asking for a prompt. Okay, it is asking from a prompt. So let's give a prompt. A dog is flying on the sky. Let's see, this is my prompt. Let's see. Now see, it is generating the image. So guys, as you can see, this is the result I got. That means here I passed the text prompt and it is generating the image. Okay, so like that, they also have one model called DALL-E, DALL-E 2. Let me show you. So DALL-E 2. So this is one of the model. I think recently they have also published DALL-E 3. Okay, DALL-E 3 is also there. So this is actually text to image generation model. You can give different prompt. Based on that, actually it will generate an image, right? So guys, you can open this playground and you can test different model, okay, as per your requirement. Now let's go to the dashboard. So let's say you want to create like generative AI application without writing code. So what you can do, you can use there UI interface. So from here actually you can create different assistant system and all. If you want to fine tune, these are the model, that means GPT model, you can also fine tune from this these services. It is also possible. Then it is also having batches, storage. Storage means it provides one vector database services. So you can also use the vector database services to store your vector representation. And no need to worry. I will also discuss about this vector database, why it is required, and why we'll be using vector database with our large language model. And if you click on the uses, you will see like your uses limit. That means, let's say if you are having $5 credit, so how much you have used here. So everything it will show you here. Now you can also generate the API key. I'll tell you how to generate the API key. So with the help of this API key, actually you will be interacting with our OpenAI platform. Okay, otherwise you can't use those are the model. Okay, without this API. See, all the model actually they have hosted in their server, so you don't need to download this model in your system. Everything will be accessing through the API. Okay, this is the best part here. Now this is the documentation, guys. You can see related all the tasks they created the documentation. Let's say if you want to perform any kinds of task, if you want to see the models, like what the model it is having. See, these are the models actually it is having. So GPT-4o, GPT-4o mini, GPT-3.5 turbo, DALL-E. I already told you about DALL-E. TTS, that means text to speech. Whishper. So you can see Whishper is a model. It general purpose speech recognition model. It is trained on large dataset of diverse audio and is also multitask model that can perform multilingual speech recognition. That means it's a speech model actually. Even it can also work with different languages. Okay. Even it is also having embedding model. With the help of embedding model, we can generate vectors. And why we have to generate the vectors, I think I already told you in the text preprocessing and text representation session. So first of all, what we have to do, we have to let's say convert our text to embedding representation for our model. Let's say you want to fine tune. Okay, you want to fine tune this OpenAI model. That time what you have to do, you have to use this embeddings. Okay, to fine tune. Let's say you want to create any kinds of generative AI application. Definitely you have to first of all generate the embeddings, okay, of that particular text, whatever documents you are having. So that's why embedding models are required. We'll also learning how we can use this embedding model whenever we'll be doing the projects. That time actually we'll be learning. Now it is having also some GPT based model, you can see. So these are the GPT based model. Okay, this is called actually completion model. We can use completion API only, okay, to use this model. I'll tell you how to use them and all. See, everything they have given. Okay, everything they have given. Let's say if you want to do the fine tuning, so there is a fine tuning guide they have also given. Okay, so all the information they have given in the documentation, and this is the one of the best resources to learn this OpenAI. If you want to, let's say, learn anything, just go to the documentation. They have the proper explanation with the code sample as well. Okay, great. Now this is the API reference. Now if I click on the API reference, you can see this is the API reference. That means, let's say if I want to use their let's say model and all, how to call with the help of API, even how to call with the help of Python code. Okay, everything they have given as an example. You can see different example they have given. But you can see there are so many things they have written, but I don't need all the, let's say, concept here. So whatever actually, let's say, concept you need to master this OpenAI. So I will show you each and everything. That means we'll be learning about ChatCompletion API, completion API, and we'll be learning another super important concept, which is nothing but function calling. Okay, OpenAI function calling. So these are the things we have to learn here. So yes, guys, this is the overview and this is the introduction of the OpenAI. I hope you cleared. Now in the next video, we'll be generating one OpenAI API key. Okay. Then after that, actually, we'll be doing some hands-on on this OpenAI. That means we'll be accessing different model with the help of API key. So to generate the OpenAI API key, so first of all, just click on the dashboard. And here left-hand side, you will see one option called API key. Just click here. And now see, I already created one API key previously. That's why it's showing. But for you, it would be completely empty. Now, if you want to create a new API key, just click on create a new secret API key. Now give the name. Let's say I want to give, let's say, test1 or anything you can give. It's up to you. Now, what you can do, you can give the permission, only read only permission, or whether actually it's restricted. Okay, you can give different permission, but I want to give permission for everything. Let's say I want to read, I want to write, everything I want to do. That's why I will be selecting all. Now I will just simply create the secret key. Now see, this is the secret key, guys. Just try to copy and try to save it somewhere, and don't share the secret key with anyone. Otherwise they will able to access your account. Okay, I'll remove it after the recording. That's why I'm showing you now. Just click on done. Now see, your API has created. That's actually you can create different API key, and with the help of one API key, you can also create multiple projects. So there is no issue with that. So guys, I think you remember I was talking about this playground, and I told you with the help of playground, you can do different tasks, and you can use different model. Okay. Now see, this model is having some of the parameter. Okay, so these are the parameter it is having. So going forward, whenever we'll be accessing these are the model through Python code, we'll be also using these are the parameter, right? So the first parameter you can see called temperature. So what is temperature parameter? See, temperature is a parameter. If you decrease the temperature parameter close to 0, that means you are telling your model, just try to be stick, okay, with the, let's say, prompt, whatever prompt user is giving. No need to take any kinds of risk, and don't generate any kinds of random output. If you are not sure, try to give I'm not sure, I'm not able to generate, but don't give any kinds of random output. That means you are giving the restriction to the model. Okay, it will only work with a true generation, okay, true data generation. Okay, this is what actually temperature parameter do. That means you can decrease close to 0. That means if you want to get a more stick output, that time you can give close to 0. And if it is close to 1, that means you are telling your model, try to take risk. Okay, whatever response you are generating, it doesn't matter, but try to be more creative here. Okay, this is the idea here. There is another parameter called maximum token. Maximum token means like you are setting the maximum tokens. Let's say whenever you are giving any kinds of prompt to the model, and model is giving any let's say model is giving output, right? And it is also a token. Okay, it is also a token, and you can set the token limit, like how many tokens you want to get as an output. So that time actually you can set this maximum token. Let's say maximum token is 256. It will give you 256 token output. Okay, I'll discuss about these tokens. So there is a token counter inside this OpenAI. With the help of, you can also count the token. Then there is another one called top P. Top P is nothing but like how many, let's say, output you want to generate from the model. How many response you want to generate from the model. Let's say top P is equal to 1, your model will give you only 1 response. Let's say top P is equal to 2, your model will give you 2 response. Okay, and from the 2 response, you can select which one is the best. Okay, that's how we can play with these are the parameter. So if you want to learn more about it, you can simply hover. So they will give you the description of this parameter and all. So these are the parameter actually we'll be using frequently. That's why I already told you here. So guys, yes, this is all from this video. So in the next video, we'll be doing the environment setup. Like we'll be doing our local environment setup, like what are the tools and let's say services you need for this generative AI project implementation. We'll be doing all the setup. Then after that, we'll be performing the hands-on, okay, of this OpenAI platform. Let's say sometimes actually we'll be using cloud services, sometimes actually we'll be using local setup. Okay, so that's why for the local setup, what are the tools and technology we need, everything will be making the setup in this video. So the first tools actually you need, which is nothing but Anaconda. Okay, Anaconda distribution. So this will give you actually Python interpreter. So inside that actually we'll be creating the environment, we'll be setting the package, okay, and we'll be implementing our generative AI application. So if you have already Anaconda in your system, it's completely fine. But if you don't have, what you can do, you can simply click on free download and you can download this particular Anaconda in your system. So I already installed Anaconda. So let me show you. So this is my Anaconda, guys. So if you have installed successfully, you will see these kinds of window like Anaconda prompt, Anaconda navigator. If you're getting this kinds of window, that means your installation is completed. And the installation process is very simple. Only just click on next and install the tool, okay, in your system. Now the next thing you need, which is nothing but Visual Code Studio. Why we need the Visual Code Studio? Because see, we'll be writing the code, okay, and to write the code I need a code editor, right? That means IDE, integrated development environment. So either you can use PyCharm, either you can use Visual Code Studio, but personally I prefer Visual Code Studio. That's why I'll be using Visual Code Studio in this particular course. Fine. So again, you can install with respect to your requirement, whatever operating system you're using, you can install this Visual Code Studio in your system. Now the next thing we need, the Git. Okay, Git is nothing but it's a, let's say, client for the GitHub. I think you know, if you have already familiar with GitHub. So if you want to, let's say, commit any kinds of code in the GitHub, what you need this Git client. Okay, and if you install the Git, actually will get one a bash terminal, which is called actually Git bash. Okay, so sometimes actually we need this Git bash, because with the help of Git bash actually we'll be executing different Linux command, because going forward we'll be implementing generative AI end-to-end projects. So there I need this Git bash to execute some of the Linux red hat command. Okay, so that's why make sure you have this Git bash installed in your system. Fine. And again, you can install from here. Just click on this button and it will download it. Then you can do the next and you can install this Git bash in your system. So as of now, these 3 tools actually I need for your local setup. And once this setup is ready, guys, then I think we can start our implementation. So in the next video, I'll show you the hands-on on this OpenAI. That means we'll be accessing different models. We'll be exploring chat, like completion API will be exploring, or completion API will be exploring function calling of the OpenAI. Okay, everything will be exploring one by one. So as I already told you, OpenAI having 2 kinds of API. That means if you want to use OpenAI model, it is having 2 kinds of model. One is like chat completion model, one is like completion model. So we'll be exploring both of them. So here we can see we are having different models. So these are the model actually related. Chat completion model. You can see these are the chat completion model. And apart from that, it is also having completion model. So if you go to the base model section, so I think there is an option called base model. Let me find. So here is the base model, guys, GPT base model. And this model is nothing but it's a completion model. Okay, it's a completion API. Now, what is the difference between chat completion model and completion model? I'll tell you. So before that, what I will do, I'll just open up my Visual Code Studio, and there I will do the OpenAI, let's say, package setup, and we'll set our API key, and we'll start our implementation. So what I can do, I can open up my local folder, and inside that you can create a folder. Let's say I will create OpenAI. Okay, OpenAI demo. Inside that, I'm going to open up my Visual Code Studio. So this is my Visual Code Studio, guys. Let me zoom. Then I will also open up my terminal. You can also open up your terminal, git bash, okay, whatever you are using, you can open it here. See, I have opened up my git bash. You can also open up your Anaconda prompt, whatever actually you are using, whatever terminal you are using, you can open it here. Okay, so I have integrated my Anaconda with my git bash. That's why you can see base has been activated. Okay, you can also integrate Anaconda with your, let's say, git bash. For this, you can simply search on Google. You will see the process. Okay, how we can set your Anaconda with your git bash. Otherwise, you can also use your Anaconda directly. Okay, it will also work. Okay, anything you can use. I'm using my git bash here. Fine. Now here the first thing will be setting our OpenAI package. See, if you want to use OpenAI, so you have to install one package actually. So if you go to their documentation, let me show you. So this is the OpenAI. So if you go to the quick start section, so first thing what you have to do, you have to export your OpenAI API key. That means you have to first of all collect your OpenAI API key, and you have to add it there. Okay, so we have already collected our OpenAI API key, I think you remember. Then second thing what you have to do, you have to install one package called OpenAI. Okay, with the help of OpenAI package, you can access all the model. That means you can access all the, let's say, ChatCompletion API, completion API, everything you can access here. Okay, now see, you can access different model. Okay, you only need to give the model name and you can access the model. Fine. So let me first of all install this package. So I'll go to my VS Code, and here I'll create a file called requirement. Okay, requirements.txt. So the first package actually I'm going to install called OpenAI. So here I'll be installing one specific version of the OpenAI, that's 0.28. Why 0.28? Because this is the stable version. So see, OpenAI has different version. Even currently they have updated their package. So in the updated package, what happens actually, so sometimes actually we'll get the error. So that's why I'm using one specific version. You can also install the latest version, it will also work fine. Now the next package actually I need pandas. Why pandas? Because I want to list down all the, let's say, OpenAI model through my code, and I want to show as a data frame. That's why I need this pandas library. Then another library I need called python.env. Why .env? Because I need to manage that secret key. Okay, secret API key, whatever API key you have collected from our OpenAI, right? .env. So with the python.env package, you can easily manage this API. That means we'll be creating a .env folder. Okay, inside that we'll be writing that OpenAI API key. Okay, this is the idea. So here, let me paste my OpenAI API key, guys. So this is my OpenAI API key, guys. I have already pasted. And here you have to give this particular key name. And here you have to give this key name, OpenAI API key equal to, you have to pass your API key here, whatever API key you have created. Okay, I think you remember, in the double quotation. Now let me save. Fine. Now let's me install this requirement. So guys, before installing, these are the package. First of all, you have to create a virtual environment here. So to create the virtual environment, you can execute this command, conda create -n. Give the name of the environment. Let's say I will give OpenAI. Okay, OpenAI demo. This is my environment name. And I have to specify my Python. So here I'll be using Python 3.10 and -y. And why 3.10? Because again, 3.10 is the stable version of the Python. Okay, that's why we're using, because it supports all the library. Okay, and -y means I want to create, I am giving the yes permission. Now see, if I execute the command, it will create the 3.10 environment inside my Anaconda. Then after that, we'll be activating, then we'll be installing all the requirements there. This is the idea. So guys, as you can see, my environment is created. Now I have to activate it. So to activate, this is the command, conda activate OpenAI demo. Okay, it should be activate, sorry. Now see, my environment is activated. Now I'll be installing this package. So I'll just write pip install -r requirement.txt. So it will install all the packets one by one here. So as you can see, my installation is completed. Now let me clear my terminal. Now here, first of all, what I will do, I'll create a Jupyter notebook file. I'll just click on new file, and I'll create a file. Let's say OpenAI demo 1.ipynb. Okay, ipynb file is a Jupyter notebook file, and here you need to select the kernel. I'll select my Python environment. So the environment I created called OpenAI demo. So let me refresh. See, OpenAI demo is there. I'll select it. Now if you want to test it, just give the any kinds of, let's say, code here. Let's say print hello. It should execute. Now see guys, it needs this IPy kernel package to run this Jupyter notebook. So let me install. I'll click on install. So it will install all the necessary things. It needs to run this Jupyter notebook. After that, you will see that this code would be executed here. So let's wait. So as you can see, all the necessary package has installed, and now I'm able to execute my code in my Jupyter notebook. Fine. All right. Now we'll be importing some of the library here. So let me import operating system. Then I need my OpenAI. Then I also need .env. So to import the .env, you have to import like that from .env import load.env. Okay, load.env. Now see, if I execute, it will import all the library. Now if you want to check any version of any package, simply you can write this command. So pip show. Let's say I want to see the OpenAI version. I'll give OpenAI here. Now see, it will show you the summary of the OpenAI name, version, summary, okay, homepage, author, everything it will give you. Okay, now the first thing what I have to do, I have to set my OpenAI API key. If you check the documentation, I showed you in the documentation, this one, this documentation. If you check the documentation, so the first thing what you have to do, you have to set the OpenAI API key. Okay, and if you're using Python program, so that time you can set the OpenAI API key like that. So just call your OpenAI package, and inside OpenAI package we have one attribute called OpenAI API key. Okay, API key. So equal to first of all, what I have to do, I have to load my API key. So to load the API key, and to load this API key from the .env folder, what you have to do, you have to take the help from load.env package we have imported, right? So just try to write load.env. Okay, now after that, just write this one os dot get.env. Okay, get.env. Inside that, you have to pass the key name. So key name is nothing but this is my key name, OpenAI API key. I'll pass it here. Okay, and it will give you OpenAI API key. I'll store it here. Now see, if I simply print it, now see, it should load the API key. Now see, it is loading my entire API key. Fine. Now let me comment it as of now. I don't need to show. Now this OpenAI API key, I'll pass it here. Now see, if I execute this code, so it has set my OpenAI API key, okay, inside my environment. Okay, you don't need to do anything. That means OpenAI will automatically load this API key right now from the package itself. Okay, now as I already told you, OpenAI is having different model. So if I click on the model section, you'll see different models is there. So if you want to list down all the models, so what you can do, you can use this code snippet. So OpenAI dot model dot list. Okay, it will give you the entire list of all the model. Now see, if I execute, now see, it is giving me all the list of the model it is having, but I want to only see the data. Okay, so here I'll filter out the data. Now see, these are the model. Now if I want to show as a data frame, what I can do, I can use pd.dataframe. I have to import pandas first of all. So import pandas as pd. Now pd.dataframe. And inside that, I'll pass this data, whatever I'm getting. Fine. Now see, if I execute, it will give me as a data frame. Now see, all the model ID, object, created date, as well as the owned by. Okay, see, everything it is showing. Now see, you can see different model. Now, as I already told you, there are two kinds of API you will get. One is like ChatCompletion API, and there is completion API. So here you can see we are having different model. So if I want to use, these are the model. First of all, we have to know what are the models actually. My ChatCompletion model, and what are the models actually only completion model. That means when I have to use the ChatCompletion API, when I have to use the completion API. So for this, you can simply go to the model section. Now let's say you want to use this GPT 3.5 Turbo. If I click here, now see, This model is a ChatCompletion API model. Okay, if you want to use this model, you have to use the ChatCompletion API. And if I go to the base model section, so this is a completion API. That means you have to use completion API for this model. Okay, now let me show you some example of chat completion and completion API. So first of all, let's try to see the completion API demo. Okay, let's say I want to use this GPT 3.5 turbo model. GPT 3.5 turbo model. See, so again, if I go to the documentation, so here is the model, guys, GPT 3.5 turbo. I have to use chat completion API. And how to use chat completion API? If you click here, that means you have to use chat.completion, okay, .create this particular code snippet. So let me show you. You can also write like that. So here I'll just call OpenAI dot chat completion. There is directly one function you will get called chat completion. Then you can call this create, okay, create one. And inside that, first of all, you have to give the model name. Let's say model is equal to, I want to use which model? GPT 3.5 turbo. So this is the model. So you have to give the name like that. Fine. Okay. Now the second parameter, you have to pass the masses. Okay, and masses should be a list here. Now see how to write the masses. So they have already given the example. That means the first thing what you have to give the role. So role you are giving system. Okay, system. You are a helpful assistant. That means you are giving a system prompt here. I think you know, like large language model is all about prompt. Okay, you have to give the prompt here. Then you are giving the user prompt. That means whatever user want to ask, so user will give it here. So let me show you how we can pass this prompt. So the first thing what I have to do, guys, I already written. So the first thing you have to give the role as a system. That means you are, so here the first role you have to give as a system. That means you are giving the system prompt. And what is the content of the system prompt? You are a helpful assistant. You can give any kinds of prompt here. Let's say you are a helpful assistant, you are a helpful translator, you are a helpful, let's say, chatbot, anything you can give the prompt here. So going forward, we'll be also learning about prompt engineering. There actually I'll try to clarify what are the prompts actually you are having. Okay, different prompt you can set here. Now the second role you are giving as a user. That means whatever user will ask. Okay, whatever user will ask. So if you open the ChatGPT also, in the ChatGPT backend, they have given the system prompt as well as the user prompt. That means as the user, we give our prompt in the ChatGPT, but in the backend, they have given the system prompt. Okay, in the ChatGPT, that is the idea. Fine. Now let's give one prompt as a user here. So let's say prompt is equal to, I'll give, let's say, hello, how are you? So this prompt, here it will come, okay, as a user prompt. Now it will give me one response. And that response I'll print here simply. Okay, now see if I execute the program. So it will give me the response. So it is giving invalid request added. Missing required parameter masses. You provide masses. Okay, so let me check. So it should be masses. Okay, not masses. Now see, it should work. Now see, it is giving me the response right now, and here is the response, guys. Okay, if I show you, so here is the response. Hello, I am here ready to assist you. How I can help you today? If I want to extract this content only, that means this let's say response only, what I can do, so simply I can copy this example as it is, and here let me paste. So here you can see, first of all, I have to go to the choices. Okay, because it's a dictionary, I have to take the choices. So let's take choice. First of all, I'll take the choice. Now choice is nothing but it's a list. So I will take the first, let's say, item of the list. Now I have to go inside the masses. Now I need the content only. Now see, it will give me the content only. Okay, hello, I'm just a computer program, so I don't have any feelings, but I am here to ready to help you. How I can assist you? Because every time whenever you will execute this program, it will give you different response. Okay, it will generate different response for you. This is the idea. Fine. Now what is the main benefit to use this chat completion API? That means chat completion model. See, in the chat completion model, you can pass multiple prompt. Okay, here you can pass multiple prompt. So how? Let me show you. So here I have given one example. So this is the example, guys. See, here I have created actually 3 prompts. Hello, how are you? Second prompt, I am 25 years old. I am a programmer. Now, third prompt I have given, tell me about me. That means in the prompt itself, I have given my data and I'm asking, tell me about me. Now, see, the same way I have created my ChatCompletion API. I have initialized my model. And in the message section right now, you can see the first role actually I have given the system role. That means you are a helpful assistant. Second role I have given my first prompt. Third role I have given my second prompt. And fourth role I have given my prompt 3. Okay, that means you can pass multiple prompt here. This is the main benefit to use this ChatCompletion API. That means in the ChatGPT also. So if I go to my ChatGPT, let's say, here I give my data. Hey, let's say I'll give the same prompt here. This is the prompt I want to give. I'm 25 years old. I'm a programmer. Now you can see memory updated. It has memory updated, right? Now if I give this prompt, tell me about me. Now it is telling you are 25 years old programmer who created courses and playlist. Okay, see, now it is giving me the answer related my information because it has remembered. Okay, it has remembered my previous prompt. So this is what actually they're using something called ChatCompletion model. That means it can understand multiple prompt. Okay, not one prompt. It can understand multiple prompting. So here you can see I have given one demo. So I'm giving the same thing. Hello, how are you? I'm 25 years old. I'm a programmer. Tell me about me. Now see, if I execute the program right now, it will able to give me the answer. See, based on the information you provided, you are 25 years old programmer. Is there anything specific you would like to know or discuss? I hope it is clear now. What is the use of ChatCompletion API and what is the benefit to use the ChatCompletion API model? That means ChatCompletion model. Got it? Great. Now we'll be tweaking some of the parameter here. So the first parameter will be tweaking, which is nothing but max token. Okay. So what I'll do, I'll copy the same example, my previous example. Now instead of asking this question, I'll write what is Python. Let's say this is my question. Okay. Now there is a parameter you can set called max token. Max underscore token. Let's say I want to generate only 25 tokens. Okay, 25 tokens. Now see, if I execute the program right now, it will only give me 25 tokens output. Now if you want to see that, you can copy and you can go to the OpenAI token. Okay, tokenizer. Now go to the first website. Now here you can simply give it this particular, let's say, a response you have copied. Now you can see maximum token 25. That means whatever token limit you have set, so it will give you that particular token output only. Now if you want to see the detailed information, you can simply print the response instead of printing the content. Now see, so now if I execute this program, you'll see that my completion token 25. Fine. Now it will charge you based on the token limit. So if you can go to the OpenAI pricing. So in the pricing section, they have given how it will charge you. So guys, as you can see, this is the OpenAI pricing page. So here they have given the pricing as per the token limit. You can see this is the input token, this is the output token. That means if your input token is that much, that means 1 million. And if your output token is, let's say, 1 million, so you will charge that many of dollar. Okay, that much of dollar. So you can see this different examples. So this is GPT-4o mini. This is the embedding model. You can see if your input token limit is 1 million token, and if your output token is, also 1 million tokens, so he will get 0.020. Okay, $20 only. It's like very less amount. Now see different model with respect to their different price. Okay, so you can check all the models. See audio model as well as the image model, assistant API. Okay, see whatever assistant API actually you will be using, and vector source. Okay, every model they have given the pricing. Okay, every model they have given the pricing. So that means it will charge based on the token limits. Let's say whatever token it is giving you the output, as well as the whatever tokens actually it is receiving as an input. It will first of all do the count operation. How it will do the count operation? So with the help of this tokenizer, so they have one inbuilt tokenizer inside that it will automatically make the count. Now you can see I'm having total 141 character. Now you can see like how many character they are considering to calculate only one token. I think 4 to 5. Okay, 4 to 5 character they are considering to count one token here. Okay, this is the idea. So here they have written, you can see a helpful rule of thumb is that one token generally correspond to 4 characters. Okay, whether it's a 4 character or sometimes it would be more than 4 character of text for the common English text. Okay, this is called actually one token. So they have given each and everything you can export here. Now let's get back to my code editor. Now I think this parameter is clear. Okay, what is max tokens here? Now I think you remember in the playground also I showed you this parameter. So if I go to the playground, see in the playground also I showed you this parameter max token. Okay, now it is, I think it is clear. Now I'll show you the next parameter right now. So the next parameter is nothing but our temperature parameter. So you can see I've given the same example, but one parameter I'm using called temperature. And I already told you what is temperature parameter means. It will give the randomness, okay, randomness to the response, like how much randomness you need. Let's say if it is close to 0, your model will be more stick to the, let's say, prompt you have given. And if it is close to 1, that means it will try to take some risk and it will generate some random output as well. Now let's say here I have given 0.6. That means I'm telling my model try to be actually balanced, okay, balanced with the prompt user is giving. Try to give some creativity somehow, even also try to be strict with the prompt user has given. Now see if I execute the program. Now see, now the response actually I'm getting, this is the this little bit different response from the previous response you can see. So here is the response I was getting. Python is a high-level internet programming on simplicity and reusability. It supports multiple paradigms. Okay. Now see, this is the another response actually I'm getting. Okay, that's how you can increase and decrease this parameter size. But what I saw, like people are using this parameter around 0.5 to 0.6 to 7 like that. Okay, no need to decrease and no need to increase much. But if you sometimes need it, you can increase, otherwise you can decrease. Okay, it's up to you. Now there is another one, that n parameter. N parameter means it will give you like how many response you need from the model. Let's say if n is equal to 2, it will give me 2 response. Now if I execute the program, see, it has given me 2 response. So this is one response and this is another response. Now if it is 3, it will give you 3 response. See, 1 response, 2 response, and if I open in a text editor, 2 response, this is 1, this is 2, and this 3. Okay, that's how you can get multiple response if you want. So this is called actually n parameter, like number of response you want to get here. Great. So yes, these are the parameter you can play with, guys, because these are the parameter we'll be using frequently. Now see, with the help of ChatCompletion model, you can perform different tasks. So let me show you. So you can give different prompt. So let's say here I have given a prompt, give me a sentiment of this sentence. Okay, this movie is amazing. Now I think you know this sentiment would be positive. Now let's see whether my model is giving me right answer or not. Now see, this sentiment of the sentence, this movie is amazing, it's a positive. That means it's working fine. Now apart from that, you can also give any other prompt. Let's say I'm given, give me the Hindi translation of this sentence, this movie is amazing. Now see, it should give me the Hindi translation. See, so whatever things we used to perform in the ChatGPT, na? Okay, that means we can perform multiple tasks. I want to do language translation, then sentiment analysis, anything I can perform here. The same thing you can also do here. Okay, because it is using the same model only. Okay, and we're able to access those model with the help of API key. That means whenever you are sending this request, it is first of all calling that API, and API is actually hitting the model, and model is giving me the response, and this response actually we are able to see. This is the idea only. I hope you clear. Now let me show you another prompt. Let's say detect the language of this sentence, this movie is amazing. So the language should be English. See, it is an English language. Okay, now you can also generate code. Okay, you can also generate code with, these are the model. So I've given a prompt, give me a Python code to add 2 numbers. Now let me see. See, this is the code I have given to add. So here I got the code to add 2 numbers in Python. Okay, so that's how actually we can create different application with these are the large language model. Fine. So yes guys, this is all about our ChatCompletion API. Now let's try to export the completion API as well. So as I already told you, so here is the definition of completion API, guys. You can see hooks you up with text completion from a single prompt. That means it can only support single prompt. You can only pass one prompt here. In the other hand, actually in the chat completion, you can give multiple prompt to keep the conversation flow intact. Okay, as I already told you, you can give multiple prompt, and that prompt actually this model can remember. But in the completion API, you can only pass the one prompt here. Okay, this is the idea. In completion API, you can pass only one prompt. Now, if I show you some completion model section, and let's say this is the GPT base. So this is use actually completion API, and these are the model are available related completion API. Okay. Now let me use this Babes 002 model, and let me show you one example. See, if you want to use completion API, that time you have to call this completion OpenAI dot completion. Okay, OpenAI dot completion dot create, not chat completion. You have to call completion only, and inside that you have to give the model first of all, which model you want to use. Let's say I want to use this Babes model, that Babes model. Okay, and it will take the prompt. So let me define a prompt here. Let's say this is the prompt. Okay, what is Python? This prompt, I'll pass it here. Now I'll print the response. Okay, now if I execute, now see, it is giving you the response. Okay, it is giving you the response. So that's how actually you can give actually only single prompt here, and whatever, let's say parameter you saw, temperature, then maximum token, then in parameter, you can also give the same parameter in the completion API as well. Okay, it will also work. But see, we'll be using the chat completion API a lot. We'll be using chat completion model a lot going forward. Okay, because I have seen like people are using this chat completion model a lot instead of completion API, because here we can pass multiple prompt. Okay, this is the main advantage. Okay, I hope it is clear. So yes guys, this is all about our chat completion API as well as the completion API, and this is all about a hands-on part on the OpenAI platform. Okay, because see, going forward we'll be using these are the concept only to implement any kinds of project. Even I will also implement some of the project. I'll tell you how we can implement different projects with the help of OpenAI. That time also you'll see I'll be using these are the concept only. Okay, now in the next video we'll be learning about another super important concept inside OpenAI called function calling. Okay, again it's the very powerful concept inside OpenAI. So we'll be learning that function calling. See, first of all, you have to understand what is function calling and what is the use of the function calling. So for this, I will go to my Blackboard and there I'll try to clarify. Okay. See, function calling helps the OpenAI model to interact with different third-party API. Let's say here you are having one API. Let's say here you are having one API. Okay. Let's say you are using one databases. Okay, databases. So let's say with the help of API, you are hitting the database, and database is giving you some kinds of response, which is nothing but a JSON response. Because most of the time, whenever you will use API, right? API to hit any kinds of website or database, you will get the JSON output. Let's say this is a weather. Okay, weather database. And with the help of weather API, you are hitting this website and it is giving you the JSON response. That means weather related data. Now what you can do with the help of function calling. Okay, with the help of function calling inside OpenAI, you can use OpenAI API, okay, to interact with this model. Because let's say this is my large language model, okay, OpenAI model. Now with the help of OpenAI API key, what I can do, I can interact with this model. That means with the help of function calling, what it can perform, okay, it can perform the communication with this data. Communication with this data. That means this model can directly communicate with this data. That means whatever response you are getting from this database or let's say API, you can directly communicate. Okay, you can directly communicate with the help of your large language model. Okay, this is the main power actually this function calling will provides. Okay, that means you don't need to manually extract this information and manually let's say feed inside your model. You don't need to do like that. You'll be using function calling, and what your model will try to do, it will directly, let's say, communicate with this particular response. Whatever JSON, whatever response you are getting, it will directly do the communication. Okay, so that's why with the function calling, my large language model will be capable enough to communicate with any kinds of third-party API. Okay, third-party API. This is the main benefit to use this one. And without this function calling, what you have to do, you have to manually extract the data and you have to manually fine tune this model. Okay, manually fine tune this model, and again it's a very hectic task, like, because again it's a large language model and you can't do the fine tune, okay, easily. Okay, and again it is having lots of cost involvement. So that's why this function calling helps us to do this communication. That means instead of like feeding the data in my model directly, function calling will try to make the communication between my response of like API response I'm getting and this particular model. Okay, this model will try to communicate with my output. Okay, it can be any kinds of API. It can be not only weather API, it can be any kinds of API, any third-party data. Okay, so that's why OpenAI supports actually different third-party actually integration. You can connect like different platform. You can connect, let's say, Slack. You can connect, let's say, different website. You can connect different database. Okay, directly you can connect, and it can directly do the communication with the help of function calling. Okay, now let me show you one example. I think then this part would be more clear. So what I'll do, I'll go to my code editor, and here I already created one file. You can see now we'll be exporting the function calling here. Again, what I will do, I'll import all of the library. Then I'll select my kernel and I'll set my environment variable. Now I can use the same example from here just to test whether everything is working fine or not. I can copy. See, everything is working fine. Okay, there is no issue. Instead of printing all the response, I can only print the content. So as I already told you, it can actually communicate with any kinds of third-party API. So as a third-party API, what I will do, I will use one API here. So called Rapid API. Okay, Rapid API. So inside Rapid API, you are having different API, whether it's a weather API, okay, any kinds of API it is available. So this is the link. So let me open this link, guys. I will search on Google. So this is the rapidopenai.com, and make sure you have created one account. So for me, I already created one account. Okay, for you also you have to create one account. Now here, what you have to do, you have to search for the API. Now simply left hand side, you can click on view all categories. Now I need actually weather API, so I'll simply search here. Weather. Now see, different weather API is coming, but I need this AI weather by Metro source. Okay, this one, I'll click here. Now see, initially if you're doing it for the first time, you will see one button here, subscribe. Okay, subscribe to the API. You have to do the subscription. That means you have to take the basic plan, that free plan. Okay, you can also take the premium subscription, but you can take the free plan. Free plan actually will give you some of the API request you can hit, right? Now I already do the subscription, that's why it's showing me test endpoint. Now simply what you need to do, you need to copy this code snippet. Copy this code snippet, and with the help of that, I have written a function. Let me show you. So this is the function I have written. So the function name is get current weather. Okay, so it will take the location and it will return you the current weather in that particular location. Okay, see, this is the UI. That means the same code, na? Here, see, the same code actually I've copy pasted. Same code I've copy pasted. You can see the same code I've copy pasted, and this is my API key, Rapid API key, and this is my Rapid API host. And don't share with anyone, otherwise they will also able to access your account. Okay, I'll delete it after the recording. Now with the help of request package, I'm sending the request and it will give you the response, and that response actually I'm doing the returning, and as a JSON format, because I already told you, na, that's any kinds of API will give you as a JSON response, and that particular JSON response I want to do the communication with my large language model. Okay, this is the idea. Now I think, yeah, everything is fine. Now let me execute this function. Now if you want to test what I can do, I can call this function. Inside that I can give any location. Let's say I will give Delhi, and it will give me response. Now see, Delhi place ID, area, India, latitude, longitude. Okay, see all the information it is giving me. Okay, all the information it is giving me related Delhi. You can give any kinds of place. Okay, it's up to you. You can give Bangalore, Delhi, Mumbai. Okay, anything you can pass here. Now if I show you the response, so this is the response. Okay, so this is the response I'm getting as a JSON. Fine. Now what I will do, I'll just connect my large language model with this response. Okay, with the help of function calling. For this you need to create a functions. See, this is the function format you have to follow. It's actually, you can see again, it's a kinds of JSON format only. So you can see I have written a list. Inside that I have mentioned a dictionary only. Okay, so this is called actually function. Again, if you go to the documentation, If I go to the documentation, let's say documentation, so they have one function calling. You can also search here, function calling. See, whatever things I explained, they have written here also. Now see, this is the format you have to follow. Okay, this is the format you have to follow. That's how you can write the function calling here. So I already simplified this thing and I written a function. Okay, so similar like format you can also follow. Now first thing you have to give the name. So current, get current weather. So I've written my function name here. You can see is the function name, get current weather. That means this will hit that particular function because this is my third-party API. Okay, you can also consider database here, but as of now I'm considering the function. Now this is the description, get the current weather in given location, parameter, object properties, location, string, and the final thing, required location. That means it needs the location. Okay, if it needs to give any kinds of output, first of all it needs the location because my function takes the location out input. Okay, I hope it is clear. Now let me initialize my functions. Now I think remember whenever I was using this ChatCompletion API, okay, ChatCompletion model, that means I can give multiple prompt. I can add multiple prompt, okay, in that particular, let's say, message section. So that concept actually will try to utilize here. See, here I've given an example. Let's say this is, here I'm using ChatCompletion model and I have to prepare the message function. I think remember this message function, inside that I can give multiple role, right? That means multiple prompt. So what I'm doing here, I'm appending one prompt here. You can see user message dot append, because it's a list. I can append role, user, content, user message. Okay, now it will add this particular prompt inside my message. Now see, if I execute, now if I show you the, now see, if you want to see the output, see this is the output, hello, how I can assist you. Now if you want to see the message only, now see in the message one prompt has been added. Okay, this is the user prompt has been added. That's how I can also add multiple prompt. Again, what I can do the append operation. See, again, I have taken another user message. What is the temperature of Delhi? Now I'm appending in the message. Now role, user, content, user, because this is a user. Okay, user message only. Now again, I'm adding the message and I'm also adding the function calling I have defined now here, this particular function calling. So with the help of this function, it will try to understand, okay, I need to execute this get current weather. Okay, this particular function, and this particular function will return the JSON output. That means the data related weather. And it will automatically connect the large language model in that particular data. See the same diagram I showed you now here. It will give you the response and my large language model will connect through function calling. Okay, now so let me show you. So if I execute it, now if I show you the message, now see two messages has been added, two prompt has been added. Hi there. Now second prompt, what is the temperature of Delhi? You can also ignore this prompt. I've just only given because I just wanted to show you, okay, whether you can add any new prompt or not. Okay, this is the idea. Now, if you see the completion, that means the response. See, this is the response you got. See, as of now, it is only calling the function. You can see it is only calling the get weather function. Okay, and here you have given the location of Delhi. You can see it is automatically extracting the location from your prompt. Okay, you can see location Delhi you have given. Okay, now if you want to get the information, what you can do? Now, if you want to get the actual information, what you can do, let me show you. Let's say you want to see the message. You can also see the message. This is the message. It is calling my function and this is my location. Now, this is the response. Okay, this is the response. Now, if you only want to extract, let's say the function name, what you can do, you can extract like that. So it is inside function call name. Okay, and it is my get current weather function. And if you want to see the location, so what you can do, inside function call, inside argument location, you can see argument location. I'm extracting the Delhi here. See, this is my location. Okay, now this response actually I'm getting, I need to pass to my large language model. For this, you can execute this code. Message.append response. The response actually I'm getting, I'm again adding to the message. That means as a prompt. Okay, as a prompt actually I'm adding. I think remember here now. Here I showed you. You can give multiple prompt. This prompt, this prompt. That means I was providing the data. Based on data, I was asking the question. The similar things I'm doing. The response actually I'm getting. This response, entire response I'm getting now. This is I'm passing as a prompt. Okay, as a prompt data. And on top of this prompt, I'll be asking the question, okay, with the help of function calling. See, the same thing I'm doing, appending the response, message.append. Now I'm appending the role as a function, name function, content location. Okay, this thing actually I'm passing one by one. If I show you the entire message, see, this is my entire message right now. Now I can initialize my GPT 3.5 turbo model. Inside that I'm passing my message as well as the function calling. Now it will give you the accurate response. See, the prompt you have given, the current here is the prompt you have given, I think, remember. What is the temperature of Delhi? Now see, this is the temperature of Delhi right now. Okay, and it is coming like that because it's a 32 degrees Celsius. So degree is a special character, that's why it's coming like that. Okay, you can convert to special, see, you can convert this Unicode to special character. Okay, it is also possible. Now see, here I have executed actually line by line. That's why you can see, you can also execute as a snippet of the code. It will give you the complete response. Now see, instead of giving Delhi, I can give, let's say, Mumbai. Now let's see the Mumbai temperature. See, it is not able to fetching the Mumbai temperature currently. So what I can do, I can give any other location. Let's say I'll give, as of now, I can comment this to line. It's not required. I'll give, let's say, Bangalore. Now see, this is the current temperature of the Bangalore. Okay, so that's how actually you can give any kinds of information, any kinds of API you can connect with your large language model with the help of this function calling technique. And it's like very powerful technique, guys. Trust me, it's like very powerful technique. Okay, if you're interested in learning more about it, like what are the things you can connect, you can go to their documentation. Okay, they have written each and everything. What are the things you can connect with it here, right? Okay, so yes, guys, this is all about from this video. I hope you liked it. Now in the next video, we'll be implementing one projects, whatever concept we have learned so far. The project name is Telegram bot. Okay, Telegram bot with the help of OpenAI. That means we'll be creating a chatbot and we'll be integrating with the Telegram. Okay, so all the fundamentals we have already discussed. Now it's time to implement one projects with the help of OpenAI. So in this video, I'll show you how we can implement one Telegram chatbot with the help of OpenAI. That means here we'll be using one ChatCompletion model. That means one large language model we'll be using called GPT 3.5. And with the help of that, actually we'll be implementing one chatbot and we'll be integrating this chatbot with the Telegram platform. Okay, so make sure you have the Telegram, guys. It can be a smartphone Telegram application or it can be your desktop application as well. Anything you can keep, both will work. Okay, so here I'm going to use my desktop Telegram. You can also use your smartphone Telegram. It will also work fine. So before starting the implementation, guys, first of all, let me show you the architecture diagram, like how we'll be implementing the entire projects. Then after that, we'll be doing the setup and we'll be starting the implementation. So guys, let's say this is the user, that means you. So you will be asking one query. Okay, you'll be asking one query and this query will go to the front end. Okay, front end of our application. So here front end wise we'll be using something called Telegram. Fine. Then what will happen? This query will go to the backend. Backend means our OpenAI. OpenAI API. Okay, OpenAI API. Then this API will access the large language model. That means here we'll be using GPT 3.5. Okay, you can also use any other model like GPT 4. You can also use GPT 4o. It's up to you. Okay, I think I showed you how to like select different model. There is a model list. So if you click there, you will see the model ID. So that particular ID you have to write there. Okay, and this model is, I think you already know, this is a ChatCompletion model. Okay, why ChatCompletion model? Because it can take the instruction. That means multiple instruction you can give, multiple prompt you can give. Okay, you can also create with the help of completion model like the Babbage one. Okay, I already showed you. It will also work, but what I feel like this ChatCompletion model will be more powerful. Okay, this is the idea here. Now what will happen? This large language model will give the response. So where it will give the response? It will give the response to the backend API. That means your OpenAI API. And OpenAI API will send the let's say response to the front end. Okay, front end means our Telegram. Okay, and from Telegram actually user will again get the response. Okay, response. Let's say this is the response and this is the question. Okay, so that's actually we'll be implementing the entire projects. Okay, this is our actually high level architecture of our project. Now what I will do, first of all, I just need to get my OpenAI API key, and I already told you how to get the OpenAI API key. So make sure you already created your OpenAI API key and you keep it with you. Now in my computer, I'll just create a folder here and I'm going to name it as Telegram chatbot. Okay, Telegram chatbot. And inside that, I'm going to open up my Visual Code Studio. Then I'm also going to open up my terminal here. You can also open up your command prompt. Then you can also open up your Anaconda prompt. It's up to you. Now here, the first thing what I have to do, I have to create one virtual environment. So to create the virtual environment, just write conda create -n. Give the name of the environment. Let's say this is my Telegram. So I'll just write telebot. Specify the Python version. Let's say Python is equal to 3. Let's say 8. Okay, I'll use 3.8. You can also use 3.9, but let's use 3.8, then -y. Yeah, now let's create the environment. So my environment is created. Now let me activate. Just write conda activate telebot. Now let me clear. Now what I will do, I'll just create a requirement.txt file. Requirements.txt. So inside that, I need to mention all the, let's say, library I need to implement this project. So here you can see front-end wise, actually, I'll be using Telegram. Okay. And to integrate my chatbot with my Telegram, I need a Python package. That means this package will communicate with my Telegram. So inside Telegram, we'll be generating one, let's say, API token. So with the help of API token, we'll be communicating with our Telegram app, right? So for this, actually, we need one Python package. So let me show you this package, actually. The package, actually, I'm going to use. So guys, as you can see, this is the package, actually, we'll be using. The package name is AIOgram. So as you can see, AIOgram is a modern and fully asynchronous framework for Telegram bot API. And this is the complete documentation of this AIOgram. Even they have also given the sample code, like how we can connect with the AIOgram and all. Okay, they have discussed each and everything. But you can see they have written actually too much line of code, but that many line of code actually is not required. So what I've done, I just made it like simple. And I created one basics template for you if you want to connect with your Telegram. Okay, so how you can connect for this, what kinds of code you have to use, I already prepared one code snippet. Okay, I'll share with you. So first of all, let me mention this package name inside my requirements. So the first package I'm going to add called AIOgram. Fine. Now the second package I need OpenAI, and I'm going to use the same version of the OpenAI I already used in my OpenAI demo. Then I need another package called Python .env. Why Python.env? Because I already showed you if you want to manage the secret key, so you can use this Python.env to load that secret key from the environment. That means .env file. Okay, this is the idea. Now let me save. Now what I will do, simply I'll install everything in my environment. So for this, just write this command. So pip install -add requirement.txt. So guys, as you can see, my installation is completed. Now let me clear my terminal. And now, first of all, we'll be testing our this one, Telegram, whether we are able to make the connection without Telegram or not. So for this, I'm going to create a folder here called research. Inside that, I'm going to create a file. I'm going to name it as ecobot, eco_bot. So here we'll be creating one eco functionality. That means if you're sending any messages, okay, to the, let's say, chatbot, that means to your Telegram chatbot, it will give you the same message. Okay, this is called actually EcoBot. That means whatever message actually will be giving as an input, that message actually will be getting as an output. Okay, so that means I just wanted to experiment whether I'm able to successfully connect with my Telegram or not. Okay, this is the idea here. But before that, I just need to create this .env file. Now inside that, first of all, you have to write your OpenAI API key. So let me just write my OpenAI API key. So this is my OpenAI API key. I think you remember I already created this API key. Okay, now let me save. Now just open up your Telegram app. So here I'm using my desktop Telegram. So you can see this is my desktop Telegram. To search for bot father. So after searching bot father, you will see different bot father, but you have to take the verified one. You can see this is the verified one. Now just try to open it up. See, I've already opened. Now see, previously I already created some of the bot with the help of bot father. That's why it's coming. That's why here you can see some of the like older messages. But if you are opening for the first time, you won't be seeing any kinds of messages. Okay, you will see a start button. You just click on the start button. Okay, then it will give you the suggestion. Okay, what you want to do here. So here I want to create a, okay, I think my screen is visible. Okay, so here I want to, let's say, create a new, actually Telegram bot. So for this, what you can do, you can write this command new/new, okay, new bot. You can see new bot. Just select this one. Now see, now it will ask you, all right, a new bot, how are we going to call? Okay, please choose a name for your bot. Now you can give any kinds of name here. So let's say I will give my live, okay, my live bot, let's say 24. Let's say this is my bot name I want to give. Now if I hit enter, see, it's telling good. Now let's choose a username for your bot. It must end with bot, like this is example Terry's bot or Terry's underscore bot. Okay, so you have to give a username, and that username should contain underscore bot, okay, at the last. So I'll give the same name, let's say my live bot, okay, 24 underscore bot. Now if I hit enter, now see, my bot is created. Now it is telling congratulations on your new bot. You will find your bot here. But before that, what you have to do, you have to collect this user, you can see use token. So let me collect this user token. I'll copy. Okay, and I'll open up my Visual Code Studio. Inside environment, what I will do. So here I'm going to paste it as of now. And you need to also give the key name. That means this is my Telegram bot token. Okay. Now I'll be mentioning inside my string. So here we have collected two secret key. One is my OpenAI API key. Another one is your Telegram bot token. So with the help of Telegram bot token, we'll be authenticating with our bot actually we have created here. You can see this is my bot. If I click on the URL right now, see, this is my bot. Now if I click on the start, now see, there you won't be seeing anything because this is not connected yet. Now see, if I send any message here, so you won't be getting any kinds of response because as of now, we haven't made the connection. So here, first of all, we have to make the connection. And how to make the connection? With the help of this Telegram bot token. Okay. And this OpenAI API key, we need to access our GPT model because this is my main large language model, right? With the help of that, actually, we'll be getting the actual response. This is the idea here. Fine. Now in the EcoBot, I'll be writing some of the code to connect with my Telegram. Okay. So as I already showed you, so this is the AIogram documentation and they have given the code snippet you can use to connect with the Telegram, right? But I already told you this, that much of actually code is not required. So I just created a basics template. Let me show you. So here, first of all, let me import some required library. So you can see I have imported some required library, but here it is coming this YOLO mark because I haven't selected my current environment. Right. So right hand side below, you can see there is one option. So my base environment is selected. Now I have to select my own environment, which is nothing but Telegram bot. Okay. Now see, this error will be disappeared. Now see, these are the packages you have to import, like login, AIogram. From AIogram, you have to import bot, dispatcher, executor, and types. Okay, if you see the documentation also, they are importing the same thing. See, they're importing the same thing as well. Fine. But as I have told you, they have written so many lines of code. I just simplified the code. Okay, that's why my code might be a little bit different. Okay, from the documentation. This is the idea. Now .env I'm loading because with the help of .env I'm going to load by .env. Okay, that means my secret. Okay, inside my environment. Now operating system I need because with the help of operating system I'll be loading. Now os.get.env, I think you remember previously you also did the same thing. And why logging is required? Because if you see the AIogram, if you see the diagram, they are also using login. Okay, so you have to write the login. Okay, login here. See, basic config login. So by default, it will take the log because it will, let's say, log all the information in the backend. Okay, because see, this is their implementation. They are suggesting to use, these are the, let's say, code snippet. Okay, that's why I'm using. It's not my implementation. So whenever you are using any kinds of, let's say, framework or library, first of all, try to check their documentation, whatever things they are suggesting. Based on that, you have to write the code. Okay, no need to do any modification at the very first. If you understand their implementation, then you can do the modification, but the core implementation you have to always keep as same. Okay, this is the idea here. Now the first thing what I have to do, guys, I have to load my API key, right? So for this I can use this load env. Now simply os dot get env, inside that I can pass my key name. Let's say I want to load my Telegram bot token. I'll pass the key name here. Fine, so it will return me my Telegram bot token. Now if I print this one, my Telegram bot token, now see, if I execute the file right now, it will print the bot token. So let me show you. So Python, let's say it is inside my resource folder, resource. I want to execute this ecobot. Okay, sorry, ecobot.py. So guys, you can see it is throwing me one error. It is telling from AIgram import bot dispatcher executor types. Import error, cannot import the executor from AIgram. Okay, so it is throwing me one error. So to solve this error, what you have to do? So you have to create actually Python, let's say interpreter 3.7. That means Python environment you need 3.7. So let's create another environment. So I'll just write conda create -n. Let's give the name, let's say my bot Python is equal to 3.7. Actually I want to use -y. Okay, now let me activate conda activate my bot. Now let me clear and let me install the requirements right now. So pip install -r requirement.txt. See, it has installed all the packages in my environment. Okay, so I already installed, that's why it's telling requirement is already satisfied. But for you, it will take some time. Okay, so once it is done, now let's clear my terminal. And now if you execute the command, this command python research/ecobot.py, that means if you execute this ecobot right now, see, it should work. Now see, it is printing my API token. Okay, it is printing my API token right now, Telegram bot token. Fine, that means it is working now. Now let me comment this line, it's not required. Now what you have to do, you have to first of all initialize the login. So that's how actually you can initialize the login. So you just need to write login.basic-config label is equal to login.info. Okay, because if you check the documentation, they are suggesting like that. Okay, you have to configure the login like that. Okay, after that you have to initialize the bot and dispatcher. So this is the bot and dispatcher. So inside that you have to pass the API token. Okay, now see what will happen. You can see from AIgram I imported bot, right? Because I want to connect with my Telegram bot. The bot actually I have created. Now if I want to connect, what I need the API token, Telegram bot API token, yes or no, right? So here you can see I'm passing this bot token inside a token actually attribute. So what will happen? This bot will be initialized. That means it will authenticate with my credential. If the authentication is correct, that means this statement would be true. Okay, if it is true, that means my dispatcher would be connected. Okay, dispatcher means, let's say the synchronization. That means whatever message I want to pass. Okay, so it will go to my Telegram bot. Okay, this is called actually synchronization. So it will be connected. Okay, it will be connected. That means this is the authentication code. Okay, with your Telegram. I hope it is clear now. Fine. Then after that, I think you saw they have written different function with the help of async and await keyword. Okay, async and await keyword. So what is the use of async and await? See, this is the concept of Python. If you don't know about Python, so what you can do, you can check out our YouTube channel. Okay, so there actually I already let me show you. So guys, you can see this is our YouTube channel. So there I already created like a Python playlist. So there I already covered each and every topic. Okay, you need to master inside Python. So there I already explained what is async and await. Okay, so you can check those video. So let me tell you as a high level what is async and await. See what this async and await will do. It will keep on syncing. Okay, it will keep on syncing your update. That means if you update anything, okay, if you update anything in the code base, it will automatically get that update. Okay, that means what happens actually, let's say whenever you update anything in your code, so you don't need to send the request. Okay, you don't need to save and send the request. It will automatically sense that. It will automatically sense that and it will send the update. Okay, so this is the work of async and await. And if you want to use AIogram, you have to use this particular keyword. Okay, async and await with a function. So I already created 2 functions. Let me show you. So I'll tell you what this function will do. So this is the first function, guys. So the function name I have given command start handler. Okay, I think you saw whenever I started my Telegram bot. Okay, whenever I started my Telegram bot, so there was a start button. See, I given /start. Whenever I will give the /start, my bot will start. Okay, my bot will start. See, if I show you the bot further, if I give /start, see, bot further started and it has given me all the suggestion actually I can perform here. So these kinds of functionality I want to implement. And if I want to implement, so for this I have to create a function, and with the help of async and await keyword I have to give here inside the function. Now you have to create a decorator, your dispatcher decorator. Now inside that there is a function called message handler. Inside that you have to pass the command, like what kinds of command you want to pass. Let's see if I give /help as well in my bot further /help. So it will give me the menu. Okay, what are the things I can perform with the help of bot further. That means if anyone using my bot for the first time, they can get the information with the help of start and help. Okay, /help. So I want to give 2 commands, /start and /help. If you are passing this one, so what your bot will do? So what your bot will do, your bot will reply, hi, I'm a eco bot powered by AIogram. So this message actually it will give. Now here you can give any kinds of messages. Okay, you can give any kinds of messages. I have given this message. Now let me show you how it will work. So for this, what I have to do, I have to start my bot. So for this is the syntax you have to write. So inside this keyword, you have to write executor start pulling. Then you have to give the dispatcher object, and as well as you have to give one parameter called skip updates is equal to true. What is skip update is equal to true? I'll tell you later on. As of now, just try to remember this parameter you have to give. Okay, if you check the documentation, they're also giving the same thing. Now let me save, and now see if I execute my program, my EcoBot. See, so it has connected. Now see, it has started pulling. Now if I go to my bot, let's say this is my bot. Now see, if I give, let's say /start here. See, it has given me, hi, I'm EcoBot powered by AIogram. Now if I give, let's say /help, it will give you the same thing, because you have mentioned 2 command there. I think, remember, you have mentioned 2 command. Now apart from that, if you give any command, let's say /hello, it's not working. If you give any other message also, it's not working. Okay, that means it will only work whenever it will get these 2 command. And here you can pass any kinds of messages. Okay, I have given powered by AIogram or anything you can. Let's say powered by Buppy. Here you can give my name. So once you changed anything, just try to re-execute the code. So I'll just stop the execution with the help of Ctrl+C. Now if I re-execute, now again I will go to my Telegram, and now if I give, let's say /help, now see, it will give me, hi, I'm EcoBot powered by Buppy. Okay, I hope it is clear now. But see, it is not able to handle my casual response. Okay, let's say if I'm giving any other message, let's say hi, hello, okay, hi, hello, whatever, it's not giving me the response because I have to create another function for this. Let me show you. So here I will create a function called echo. That means it will give me the same message again and again. Okay, so this is the echo function, and see, I'm using the same syntax only, message handler. Now see, here I'm not providing any kinds of command. I'm not providing any kinds of command, because see, whenever I'm giving my casual message, this is not a command. Okay, so that's why you don't need to mention the command. That means whatever message user will give, that message actually it will send. Okay, it will show you as an output. You can see with the help of await. Now let me save, and again I have to re-execute. Let me stop the execution. Now re-execute my code. Now if I go to my Telegram, now let's say if I just write hi, it will give me hi. If I write hello, it will give me hello. If I write, let's say I am Buppy, it will also give me I am Buppy, because it's an eco bot we have created. That means I'm successfully able to connect with my bot. The bot actually I have created in my Telegram. That means Telegram connection is completed. Okay, Telegram connection is completed. There is no issue. That means we are able to communicate with the front end. Now we have to make another functionality, that means backend API. That means we will be using OpenAI API to let's say process the response, process the question whatever user is asking. We'll be taking the help from the LLM will give the response, and this response I will be sending to the front end again. Okay, so now let's create our actual application. So what I will do, outside of research, I'll create a file. I'll name it as, let's say, main dot py. Okay, main dot py. Inside that, I'll be writing all the code. So what I can do, I can import all the necessary library. Again, you can see I have imported all the library. Even I also imported here as well. Okay. Apart from that, I'm also importing OpenAI as well as the system package. Okay. This is the idea. Now see, this application I'll be creating a little bit advanced, because if I show you my ChatGPT now, so let's say this is my ChatGPT. Let's say if I give any message to the ChatGPT, let's say I need a Python code to add 2 numbers. Sorry, I think my prompt is incorrect. It should be add. Again, I can give the prompt. I need a Python code to add 2 numbers. Okay, now I think it is perfect. Now see, it is giving me the code. Okay, but see, it is giving me with the function, but I don't need the function. What I can give without functions. Okay, now see, I just given without function, it will automatically remember I'm asking this particular response. Okay, it has remembered. Okay, it has remembered my previous input. So this is actually using one memory. Okay, temporary memory. So I also want to implement this kinds of temporary memory inside my chatbot. So for this, what I will do, I'll just write a class here. I'll just name it as reference. Okay, reference. So inside that, what I will do, I'll just write a constructor, and this will, and it will return actually none. Okay, so inside that, I'll just write self dot response, and it should be empty initially. Okay, that means as of now, let's consider this is my empty memory. Okay, this is my empty memory. That means whatever question I'll be asking as a as a temporary memory, that question actually I'll be saving here, so that if I want to ask any new question, my previous question my model will try to understand. Okay, it will try to remember. Now here you can also pass the doc string. So let's say this is my class I have written to store previously response from the ChatGPT API. Okay, you can also give OpenAI API. OpenAI API. Okay, this is the idea. Now let me load my OpenAI API key as well as my this Telegram bot token. So first of all, I will load my OpenAI API key, and I'm setting my OpenAI API key. Then I will also load the Telegram bot token. Okay, this is my Telegram bot token. Fine. Then let's initialize this reference class. So here I can initialize. I'll just write reference is equal to my reference. Then I'm going to define my model name. Let's say which model I want to use. So model underscore name is equal to, let's say I want to use GPT 3.5 turbo model. If you go to the OpenAI platform, okay, if you go to the OpenAI models, see, here is the different model, and I want to use this 3.5 series actually, C turbo model. Okay, this model actually I'm using right now. Fine. Now, same way, I have to initialize my dispatcher as well as the bot, because it will authenticate with my Telegram. The same code, guys, from my previous, let's say, file I'm copy pasting. Okay, I think you remember. So we are initializing our bot and dispatcher. So here, the first thing I want to create a function. So this function actually will do the welcome. Okay, so if you give, let's say, start command, it will welcome you. So this is the function I've written, guys. You can see simple function using the same concept. Okay, same concept. So this is the function dispatcher message handler, and here is the command only start. Okay, if you give start command, it will give you, hi, I am a telebot created by Bappy, how I can assist you. Okay, this is the message actually it will show you. That's it. Now if you want to execute, you can simply copy this line, and here you can paste it. That's it. Okay, now it's a dispatcher object, DP. Previously I written as a short form, but now what I did, I just written full name. Okay, this is the idea. Now let me execute and let me show you. So I'll open up my terminal. Let me stop the execution. Now let's say if I execute the file right now, I need to execute my main.py file. So clear Python main.py. Now see, if I open up my bot and if I give /start right now, see it is giving, hi, I'm a telebot created by Bappy, how I can assist you. That means it is working fine. Now let me stop the execution. Great. Now I also want to create a helper function. That means I showed you now, if I go to my bot further and if I give /help, so it will give me all the menu actually I want to perform here. So I also want to give one menu function in my bot. So for this I have created a function and I named it as a helper. See, this is the function. So it will take the help command. After that it will show you this message, hi there, I'm a ChatGPT Telegram, or I can write, I'm a Telegram bot, okay, created by Bappy, please follow this command. Start to start the conversation, clear to clear the past conversation, and help to get the help menu. Okay, I hope this helps. Now it will give you this this actually menu. Okay, now see here I've written clear /clear to clear the previous conversation. Now let's say if you're saving any conversation and if you want to clear it, so you can use the clear function for this. So what I will do, I'll just write a function named clear. So here I can write, so it will just do the clear operation on the previous conversation. See, I think you remember we initialized our reference here. So inside reference, we're having one variable, class variable called reference. So here I'm doing the clear operation. See, reference.reference I'm making as empty. That means whenever I will save something, okay, inside the variable, and if I call the clear past function, it will clear that particular response. Okay, this is the idea. If you go to the ChatGPT as well, and if you write forget my past prompt, it will forget that. Okay, it will remove that memory. So same way, I'm creating the same functionality here. And to execute this clear past, so I will pass one command. So I'll just write clear, this command clear. So it will automatically do the clear operation. So for this, I will be writing another function here. So function name is clear, and it will take the clear command and it will call this particular function. You can say clear past. Okay, then it will give you message, I have cleared the past conversation as the context. Okay, this is the idea. Now I have to write my main code. That means my main brain functionality of my application. So for this, I already prepared the OpenAI code. See, this is the OpenAI code, and this is nothing new, guys. This is nothing new. Just try to see. Here I'm using ChatCompletion API. Okay, now let me check everything is fine or not. Now you can see, guys, everything is fine. So I'm creating the ChatCompletion API and role assistant content I'm giving, because you can see reference.response. First of all, it will check this response. Okay, this response, if there is any response or not. Okay, if not, that means it will act like a you are using for the first time. That means there is no previous context. But if you are starting for the second time, let's say, I think you remember here in the ChatGPT, I have given a prompt, I need a Python code to add 2 numbers. That means one response it will remember, and whenever I'm asking the second question, it will refer my previous, let's say, question I've asked. Okay, the same thing actually happening here. That means it will first of all check whether you are having previous response or not. If not, that means it's a completely new role. Otherwise, it will refer my previous, let's say, response. Okay, now this is the user message, then it will give you the response. This response actually I'm only getting the content, and I'm printing in the terminal, and I'm also printing in my user interface. That means in my Telegram, and it is also updating the response. Okay, you can see this reference response is also getting updated. Okay, now if you will call this clear past, it will also do the clear operation. It's a simple code I have written. Now let me show you how it will work. So I'll open up my terminal. Now let me execute my app. Now if I open my bot, let's say if I just write /start, I think this command I already showed you, na? /start /help. It is working fine. Sorry, /start. Okay, now see if I give any casual message, let's say hi. See, it is giving me hello, how I can assist you. Let's say if I give hello, how are you doing today? Let's say I'll ask, what is Python? It is telling Python is a high-level programming language. Okay, now I can also give the same prompt. Let's say give me a Python code to add, code to add 2 numbers. See, this is the code I got. Now I'll ask, give me as a function. Now see, that means it is remembering my previous context. Now if I give /clear, I have cleared all the past conversation. Okay, now if I give the same message, give me as a function. Now see here, it is giving me the function. Okay, it is giving me the function, but not these kinds of function. That means my previous, let's say, question function. Okay, that's why I've created this clear. Okay, clear functionality as well. Okay, now you can ask any kinds of question. Okay, whatever question you can ask in your chat GPT, the same question you can also ask here. Okay, there is no issue. So that means we have created one beautiful application. Now one thing I want to show you, this is keep update is equal to true. Let's say if it is true, what will happen? Let's say if my application is offline right now, let's say I'll stop the execution. Let's say it is offline. Now if I give any message, let's say hello. Now see, it is offline. Okay, it's not giving you any response. But if it is online, let's say if I execute the program right now, let's say my application is online. Okay, now see, still it is not giving me the response. Still it is not giving me the response, because let's say sometimes it's possible your application will go offline, and if user is giving any question, when it is online again, it should return the answer, right? But it's not giving. So for this, what I can do, I can stop the execution, and this parameter I can make it as false. Okay, now let's say if my application is offline, let's say hello. Now if I re-execute my program, see, it will automatically take the hello. Okay, hello message, whatever you asked during offline. Now see, it is giving you the response. Okay, so this is one of the amazing parameter you can play with if you want to, let's say, keep your application offline. But if you want to reply it, okay, when you are online, you can update this particular parameter. Fine. So yes, guys, this is the like chatbot we have implemented. You can also share this bot with your friends and family. So what you need to do, you just only need to give the username. Let's say this is your username of your bot. Now if they search with this username, they will be able to access your bot. Okay, and if they're asking any question, they will also get the response. Okay, that's how. Just try to ask your friend to use your chatbot. Okay, you have developed with the help of OpenAI.
So in this video, actually, I will show you like how you can fine tune your GPT-3 model, okay, with your custom data. So basically what I'm gonna do here, so basically here we'll be fine tuning ADA classifier, okay, to distinguish between two sports like baseball and hockey. So basically we are gonna perform one classification task here. Okay, so here I will like take one sports data, and with the sport data, okay, I will train my GPT-3 model, which is nothing but ADA. Okay, ADA classifier, I think you already know it has various model. Okay, if you click on the model, so ADA is one of them. Okay, so let's install first of all OpenAI. And here you don't have to worry about your system configuration, because here you are using OpenAI API. Okay, so all the training and all the, you can say, computation, everything will be performed on their website itself. Okay, on their you can say engine itself. Okay, so you don't have to worry about. So you just need the API key and just try to open up your Google Colab. Okay, and try to start the training. That's it. So because see, it has like millions of parameters, so it's not possible to train in our system. Okay, so that's why they have proposed a API, okay, GPT-3 API, instead of giving the raw model to us. Okay, then this command, actually you can actually upgrade your OpenAI. So let's upgrade it also. And here I will import my data. So this data actually is already available inside scikit-learn dataset. Okay, like 20 news group dataset, the name of the dataset is. Okay, so here you have two categories, one is like baseball and hockey. Now if you want to see the example, the first example, so this is the data. Basically it kinds of email. Okay, and here you have the news sports data. Okay, now if you want to see the label target, so you have sports, baseball and hockey. Okay, now if you want to see the first one, see the first example I shown here, first data set, with respect to that I'm showing my first target. Okay, which is nothing but it's a baseball. Okay, now if you want to also see the count, so you have total example 1197, baseball has 597, okay, example, and hockey has 600. So basically this data is not imbalanced. Okay, it's fine. Now inside data preparation, first of all we need to prepare the data. So what kinds of preparation we need to do here? If you see, if I show you the target, so it has actually rec.sport.baseball. Okay, so this is the additional information I don't need. Okay, so I need to suppress that. So if you just run this code, so basically what it will do, it will take all the data, okay, and it will create two columns. One is like prompt and completion. Okay, so why I'm creating prompt and completion? Because if you go to the documentation of OpenAI, so here is a section called fine tunes. Okay, just click on fine tunes. So they have given like how you can fine tunes, okay, GPT-3 model. So here one thing they have mentioned, data preparation. I think here fine tune guide, and if you just go below, prepare your data set. Okay, so if you just read it, okay, if you just read this okay, entirely, so you will get to know you need prompt and completion. Okay, so that's why I have given this name prompt and completion. So prompt is nothing but your data, okay, your input data, and completion is nothing but your level. Okay, so that's actually you need to prepare the data. So once it is done, now you need to convert them a file format called JSON-L. Okay, so this is the command, just run it. Okay, now let me show you what is JSON-L. Okay, so if you just refresh here and let me download it. Now if I open it, okay, so this is the same data format. Okay, like this is your prompt, and at the last you have the completion. See, this is the completion. Okay, and if you see, this is the same format. If I come here, this is the same format. Okay, so that is why you need to you can say convert your entire data frame to JSON-L format. Okay, is done. Now OpenAI has a data preparation tool. So if you just call OpenAI, and from tool itself you just call prepared data. Okay, so it will actually prepare your data. First of all, it will take this JSON-L. Okay, see, I'm just passing sports to JSON-L hyphen q. It will take this one and will do some analyzing. Okay, if something is okay wrong with your data set, it will throw error. Otherwise it will actually fix it. Okay, so see, I have run this command, so it has generated two file, which is nothing but sports to prepare train JSON, validation JSON. Okay, so it will also do like train test split. Okay, you don't have to do it separately. Okay, so this thing actually you need to run, and here also they have written, okay, they have their own data preparation tool you need to execute. So whenever it is done, now this is the section actually you can execute, okay, to fine tune your you can say model. Okay, this is the training command actually. So here you need to change this API key, because this is my older API key. So what I will do, I will change it with the newer one. You can also read it from secret. Okay, but I will give it here just for simplicity. Now here API fine tunes great. Okay, now here actually you need to give your data path. Okay, so this is my train data path and this is my validation data path. But here one issue actually I was having, so I was trying to actually execute this command, because here if you see, if I show you my model, okay, so fine tunes, here I have like already trained two models, okay, with the same data. So here actually you can't give the same ID again and again. Okay, if you give this same name, so it will create the same ID again and again. Okay, and it will give you error like just give a new ID. Okay, so that's why if you have done training one time, okay, you just change the data name. Otherwise it's fine. Okay, if you're doing it for first time, it's fine, just keep it as it is. Otherwise what you can do, just rename this name with a unique name. So I'll just rename, so I'll just give sports 222. Okay, because this name is already present in my model, so I'll that's why I'm changing the name sports 222. Okay, similar wise, just change it also here, sports 22. This is your validation. Okay, and computation and metrics, okay, everything you're providing, and at the last you're selecting the ADA model. Okay, epochs is not required, so it will basically okay, automatically observe whenever your loss is not decreasing or accuracy is not increasing, it will stop the execution. Okay, so now everything is prepared. Now just click on this one, so it will take the data and it will start, you can say, training your, okay, it's telling, okay, it's telling this data is missing. So let me do ls. Okay, so here one mistake I have done. Here I have given 1. Okay, 1 won't be there. So just remove the 1. And now I think everything is fine. Now let me execute again. So guys, actually training takes a lots of time. So what I'm gonna do, I'm gonna show you my previous notebook. Okay, I did the training. So basically whenever you will click on the command, so actually it will start the training and it will start the epochs. Okay, see, this is the epochs, actually it will be running. Okay, and once your training is completed, it will save your model. Okay, it will save your model. So where you will get the model, just come here. Okay, come here, and here you need to refresh this page. Okay, so if you just refresh this page, now if you just click on the model, and at the last there would be a section called fine tunes. Okay, inside fine tunes actually you will get your model. Okay, see, I trained add a model. Okay, and this is the id. Okay, it is the id, and basically this is the date actually when I trained this model. Okay, so this model actually you have to use, okay, whenever you'll be doing the inferencing. So now how you can do the inferencing? So this is the code. So basically you can also see the evaluation metrics. Okay, performance metrics actually you can see. Okay, you can also save it as a result.csv. Okay, and here you can also plot this accuracy score. Okay, this is the accuracy score, and this is my data. Okay, this data set actually I'm like taking one prompt. Okay, and here actually I'm doing the generation. Okay, basically I'm loading my model. So why do you need to give your model? So let me show you. Yeah, so here actually you need to provide your model name. Okay, the model name actually you will be training. Okay, here see, I have took this model. Okay, so this name actually you need to copy and you need to paste it here. Okay, and it will load the model from the OpenAI itself. Okay, and it will do the inferencing. See, this is the score of your hockey and baseball, and after that if you want to see, okay, this is the baseball and hockey. So that's actually you can okay, see the example. Okay, do the inferencing. So yes guys, I think you got it, like how you can fine tune your OpenAI like GPT-3 model. Okay, with your custom dataset. And if you want to learn more about fine tuning, I will suggest just try to explore this documentation. It is pretty good documentation. Just try to read everything. Not only like classification, you can also do it from summarization and other tasks. Okay, for that actually you need to prepare the data. Like you need to learn how to prepare the data. Okay, so yes guys, I think you got it. This was all about from this video. And yeah, that's it. Actually you need to learn about OpenAI and like GPT-3. Okay, so once you are comfortable with this API, I think you can do anything. Okay,
So as I already showed you the OpenAI platform, even I already use different model. Even in our previous video, we also implemented one project called Telegram chatbot. So here we'll be exporting another actually variant of the model. So the model name is Whishper. So I think I showed you the Whishper, let's say introduction. What is this Whishper model? So let me show you again. So if I go back to my, let's say OpenAI platform. So here, if you go to the model section, and if you just go below, this is the Whishper model, guys. So let me open it up. So you can see Whishper is a general purpose speech recognition model. It is trained on a large data set of diverse audio, and it is also multitask model that can perform multilingual speech recognition as well as the speech translation and language identification. Okay, so this is actually a speech based model. That means you can give any kinds of speech or audio, so it will give you the transcript of that particular audio. So here what we'll be doing, let me show you that entire diagram. See, here we'll be implementing one audio transcript translation. Let's say here I will pass one audio file. Okay, it can be mp3 or any other format you can pass. I will pass to the Whishper model. Okay, and Whishper model will return a transcript of this audio. Okay, transcript, that means it is a text. The entire audio text actually it will return. Then what I will do, I will use one actually ChatCompletion model. That means here I can use any kinds of model. Let's say here you will be using GPT. Okay, GPT-3. So I'll pass this transcript to the GPT-3, and here I will provide a prompt, translate. Okay, translate. So here as an input, you will pass one language. Okay, you will pass one language and it will give you that like translated text. Okay, translated text. Okay, so this is the entire actually high level diagram. So for this, I'll open up my local folder, and here I'm going to open up my Visual Code Studio. So this is my Visual Code Studio. Then I'm also going to open up my terminal here. Okay, I think you remember previously we created one environment like OpenAI demo. So let me activate the environment instead of creating again and again. So what I can do, I can just write conda activate OpenAI demo. Okay, so this environment I'm going to use because inside that OpenAI is already installed there, right? Fine. Now here I'm going to create a requirement file. So here the first requirement, you need the OpenAI. I think OpenAI is already installed, but here I'm adding because I want to share this material with you. So later on, whenever you want to install it, you can check the requirement.txt file. Then I also need python.env. I think you know why python.env, because we'll be managing the credential, right? That means we'll be creating a .env file, and inside that I'm going to mention my OpenAI API key. I think you remember we already created one OpenAI API key. So this is my OpenAI API key. Okay, let me save it here. Fine. Now see here, I'm going to create a user interface. That means see this audio file, user can upload. User can upload this audio file. For this, I need a web interface. Okay, web application. So to create the web application, I'm going to use one framework called Flask. So Flask is a framework inside Python. With the help of that, you can create a web application. Okay, so let me also install the Flask here. Okay, Flask. Now simply what you have to do, open up your terminal and write this command, pip install -r requirement.txt. For me, it is already satisfied, but for you, it will take some time to install all the packages. Fine. Now, the first thing, I'll show you the demo, like how we can use the Whishper model. So first of all, let me import OpenAI, and it is showing this warning because I have to select my environment. I have created OpenAI demo. Then I also need to import operating system because I want to load my env. Then .env as well. So from .env import load env. Fine. First of all, I'll load my env. So here is my OpenAI API key. os.getEnv. Then I need to add this API key inside my OpenAI API key. So OpenAI.API key is equal to my OpenAI API key. Fine. I think my authentication is completed now. Now what I will do, I'll just open up one audio file. So let me show you. I have one audio file with me. So this is the audio file, guys. Let me play. So this audio actually I have recorded. Python is a high-level interpreted general-purpose programming language. It is very easy to learn, and you can use Python programming in data science. Fine. So this is the audio file actually I have recorded. So I just need to open this file. So to open this file, I think you can use this open, and inside that you can pass this name. So recording dot mp3. Okay, mp3, and again it's a binary file, so you have to give the mode rb, read binary. Fine. So it will give you one object, let's say audio underscore file. Okay, so I have successfully loaded this file. Now if you want to get the transcripts, what you can do, you can use this OpenAI Whishper model. So I'll just write OpenAI dot audio. This is audio model, I think I told you. So you have to call one function called translate. Okay, translate, and inside that, first of all, you have to mention the model name. So I want to use Whishper 1 model. So it is having different model. I want to use Whishper 1 model. Then you have to pass the audio file. So audio file. Now here it will give me the output. Now let me print the output. Now let me show you. So guys, here is the text I am getting. Python is a high-level interpreted general purpose programming language. It is very easy to learn and you can use Python programming in data science. That means whatever things you can actually hear in the audio, the same thing you can see as a text. So it is like very powerful model. It will give you the accurate result always. Okay, you can try with different audio. I think you will get it. Now what I have to do, I have to translate. Okay, I have to translate this transcript in a different language. Okay, for this I'll be using GPT-3 or GPT-4 model, whatever you can use here. Okay, and we'll be creating one user application so that user can upload this audio there. Okay, this is what actually we'll be implementing. So for this, what I can do, I can create another file here. I'll just name it as app.py. Now I'll copy paste the same code. This code actually I'll just try to copy paste here, because here we are authenticating with our OpenAI only. Fine. Now apart from that, I also need to import another package called Flask. Okay, because with the help of Flask, we'll be creating this user application. Okay, that is why I'm importing Flask. So you can see from Flask, I'm importing Flask request. So redirect URL, this is not required as of now. Justify render template. Okay, so with the help of that, actually, we'll be rendering our web page. For this, you need a basic HTML file. I'll tell you how we can create a HTML file. You can also get different template. You can also use that one. Fine. Now, this next thing, I'll be initializing my Flask. To initialize the Flask, just write this code. This is the code, guys. Flask. In the parenthesis, you have to give underscore name. Now you can ask me how to initialize the Flask. Go to the Flask documentation. You can see that. Okay, we can see the code snippet, the basic template they have already given. So first of all, here I'll just add one configuration. So app.config. That means whatever audio actually user will upload. So this will save. So this will save actually. First of all, let me just write upload underscore folder. This will save inside a folder name static. Okay, now let's create this folder. Left hand side, I'll create a folder name static. Okay, inside that this audio will be saved. Fine, this is the idea. Now let me create a route. So I'll just give @app.route. So as you can see, this is my route. So it will look for actually two kinds of, let's say, request. One is the get request and there is like post request. Okay, if it is matching, what will happen? This will execute this function. So here I'm going to create a function called main. Okay, so this will execute this main function. So inside main function, the first thing I have to check whether it's a post request or not. So if request, okay, if request.method is equal to if it is post. Okay, if it is a post request, that means if you upload one audio file and if you click on the button, that means it would be a post request. Okay, that is the idea. If it is a post request, so what I will do, first of all, I will get the language. Okay, I'll get the language. That means user will also pass the language, like in which language he or she wants to translate this, let's say, transcript. Okay, that's why I also need to take the language input. So here I will take the input. I'll just write request.form. So from the form itself, I'll take the language. Now, how I'll get the language? Because for this, I'm going to create a HTML file. So let me create a folder here first of all. If you're using Flask, you need to create this folder, guys, called templates. Okay, templates. Inside that, I will be creating a, sorry, it should be templates, not, spelling is not correct. Now it is fine. Now inside that, I'm going to create a HTML file called index.html. Okay. Now here I have written one very simple HTML code. It will only accept the audio file. See, here I've given the title, and this is like very basic CSS code I have added here, just to like show my front end a little bit actually beautiful. That's why. Now see, it will user can upload one audio file. Okay, you can see user can upload one audio file. Input type is file, and user will also able to give the language input. That means in which language he or she wants to translate that transcript. Okay, then there would be a button called upload. So whenever they will upload, so what will happen? It will hit the post request. Okay, it will hit the post request, and that time you can see method is equal to post. That time it will hit this route. Okay, it will hit this route, and I will be able to get the language, and whatever audio actually he is submitting, everything I will get. Okay, from the backend. This is the idea only. Fine. So this is a simple HTML code. And now you can ask me why to get this kinds of HTML code. There is a one beautiful website you can follow called Bootstrap. Okay, Bootstrap. So here you will get all kinds of free HTML, CSS template. You can go to the example section and see different actually template you are having. You can get their HTML and CSS code. Even you can also search. Let's say you need a file uploader button. Okay, file upload. See different code snippet they have already given. Okay, that's how actually you can also get the code. You can also get the code. Okay, so I just referred this website and I actually let's say collected this HTML and CSS code and I modified, okay, with respect to my requirement. This is the idea. Now I think everything is fine. Now what I will do, I'll go back to my app.py and I'm getting the language. Then I also need the file. Okay, so to get the file, I'll store inside a file and I'll write request.form. Request dot not form dot files actually, because it's a file type input, right? So it should be a file. You can see here I have mentioned it should be a file. Okay, it should be a file type, should be a file. Now once I get the file, first of all I will check whether this file is available or not. If file is equal to true, okay, if this is not false, that means user has uploaded the file. That time what I will do, I'll just simply save this file. Where I will save, I'll save inside my static folder. So this is the code. I think you remember we set the configuration. Okay, static. Okay, upload file static. So it will save the inside static folder. And to save this file, I need a file name. So let's create a file name here. I'll just write file name is equal to file name. Okay, it will give you the file name. Now after that, you can easily save this file inside the static folder. Then I will load my audio. So to load the audio, I think you remembered I was using this code snippet. So I can use the same code here. Now see, this recording.mp3 would be available inside static folder. So I need to also give the path of the static. Okay, static / recording.mp3. Now the same code I'll be writing here. I'll copy and here I'm going to paste it. So this will give me the output. That means the transcript. Here I can mention it as transcript. Okay, transcript. Now what I have to do, I have to translate this transcript to the another language. For this, I already told you here we'll be using something called GPT-3 or 4 model. Okay, so let me initialize my GPT model. So I think remember how we can initialize it. We can use ChatCompletion API. So here is the code snippet, guys. So here I'm using ChatCompletion API. Inside that I'm mentioning I want to use GPT-4 model. Okay, GPT-4 model. And this is the message I have given, role. You can see role, system, content. You will be provided with a sentence in English, and your task is to translate it to language. That means whatever language user is giving that in that particular language, then the role. So let me bring it here. I can see role, user, content, transcript.text. That means whatever text actually I'm getting after doing the, let's say, audio to text, I'm just passing it here. And here is my prompt. Okay, here is my prompt I have given to my large language model. And this is the temperature parameter and this is the max tokens. Okay, I already explained this parameter. Okay, why it is required. Now simply what I will do, I'll just try to return this response, but I will just try to return with the JSONify. Why JSONify? Because whatever, let's say, response you want to render in the HTML page, it should be JSON format. Okay, that's why I have to do the JSONify. So inside that I will be passing my response. Okay, and JSONify I already imported, I think you remember from here. Then if it is not a post request, okay, if it is not a post request, that means if it is a get request, what will happen? It will only render, okay, it will only render my index.html. Okay, this index.html, that means my web app. Okay, my web app menu, it will open in front of the user. This is the idea. And to render it, I'm using render template function. You can see I've already imported it here. Now if I want to execute my application, so you can execute it here. For this, you have to give the app host and app port. See, app.run host 000. That means I want to run in my local host, and debug is equal to true. That means if you change anything, it will automatically update the changes. And this is the port number 8080. Now let me execute and show you this application. So I'll open up my terminal. And now if I execute, let's say Python app.py. Now see, it is running on my local host. Now let's go to the Google and search for localhost port number 8080. Now see if I search. So guys, you can see this is my interface. Okay, interface of my application. Now here you can upload any kinds of audio file. Now let's upload. So let's say I want to upload this audio. Now language, let's say I want to translate in a Hindi. Okay, Hindi. Now let's upload it. Now see guys, this is the response I got. And this is my response. You can see this is the Hindi translation. Okay, this is the Hindi translation. Whatever actually I had in my audio. Now you can also give any other language. Let's say again, I will pass my audio. Let's say I want to translate let's say I want to translate in Bangla. Okay, Bengali. Now I'll upload. See, this is the Bengali translation I'm getting. Okay. Now you can also extract the content only instead of like, let's say, getting all the response, but I printed all the response. I just wanted to show you each and everything, whatever things it is returning. Okay, I already showed you how we can extract out this content, okay, from my previous, I think, session, I think, remember. Fine. So yes guys, that's how actually we can implement this project, and we can use the Whishper model. Okay, now what you can do, you can improve this project, you can add some more functionality. Let's say you want to again convert this text to audio, you can also do it. For this, just go to the Whishper documentation and try to check there. Okay, so I hope guys you like this project. So if you have liked this project guys, so please try to subscribe to the channel and share this video with your friends and family. So I already showed you OpenAI is having different actually large language model, like different kinds of large language model, like language model, multi-model, okay, image model, like different model actually it is having. So we'll be using another model. This is called actually DALL-E. So DALL-E is having different like version, like DALL-E 2 is there, DALL-E 3 is there. So we can use OpenAI API to access this model. Okay, so let me show you this DALL-E model. So guys, if you go to the OpenAI documentation, so here you will see this DALL-E model. Let me show you. So this is the DALL-E model. So as you can see, DALL-E is having different kinds of let's say version, like DALL-E 3, then DALL-E 2. Okay, so different version it is having, and DALL-E is one of the model actually. It can create actually realistic image from a prompt. Let's say here you will be passing one like text prompt, and with the help of this prompt actually it will generate the image. Okay, the prompt you will be asking the same kinds of image actually it will try to generate, and this would be realistic image. Okay, now let's see how we can use OpenAI API to access this DALL-E model, and let's build one image generator application. So what I will do guys, I have used the same template as I already used in my previous project implementation. I think you remember we are using Flask there. So I used the same template and I just did a little bit modification here. So the modification I have done, the entire HTML code. Okay, I've done the modification. So let me show you the application, like how it will look like. Let me clear. Now if I open up my app.py again, so let me go to Google and localhost port number 8080. So guys, you can see this is the interface of my application. So to build this interface, I have actually collected this HTML and CSS code from the Bootstrap website. I think I showed you that Bootstrap website, right? So you don't need to do anything. Only you can change the title and all. Okay, everything you can keep it as default, because you can use this HTML and CSS code as a template. Okay, let's say you want to build any other application with the same template, you can use this code as it is. Okay, if you're not familiar with HTML and CSS code, it's completely fine. You can copy paste from different website. Okay, now the second changes I have done, I've created two route. One is my default route. That means if user is hitting my let's say default route, that means port number 8080, so he will get this kinds of landing page. Okay, and to render the landing page, actually I'm using render template index.html. Okay, and whenever user is giving any kinds of prompt and they're submitting, okay, submitting button, so it will hit this route and it will generate and it will execute this function, and this function will take the prompt, whatever prompt actually user is giving here. I think you can see. Okay, and this prompt will go to the OpenAI DALL-E model. You can see to use the OpenAI DALL-E model, you have to use this code snippet openai.image.create. Okay, now inside that, just try to mention the prompt, number of images you want to generate, just give the number of images and the size of the image. Okay, everything you can set here. Now I'm printing the response as well as and here you can see I'm also rendering on my user interface. Okay, and again I'm running on localhost and port number 8080 and debug is equal to true, means if you are changing anything, this will reflect automatically. Fine. So this is the simple modification I have done guys. Otherwise everything I kept default. Okay, everything I kept default, whatever things we have implemented in our previous project. So yes guys, I think you got it. Using OpenAI is like very easy. Only you just need to know how we can access different model. Rest of the things you can take care. Okay, let's say if you want to create any kinds of application, you have to design how you'll be creating. Okay, otherwise the fundamental will remain same. Now let me show you the demo guys. So what I can do, I can give a prompt here. Let's say I'll give a dog is flying and smoking. Let's say this is my prompt I have given. Let's see whether it is able to generate the image or not. You can give the same prompt in the ChatGPT also. Let me show you. ChatGPT is also using this kinds of image model. Recently they have published one model called GPT-4o. Okay, GPT-4o. So this model is able to actually create this kinds of image. Okay, from your prompt. Now let me pass this prompt. A dog is flying and smoking. See, it is generating 2 response. And let me see this one. Actually, it has generated. Okay, this is a cartoon version. Even you can also generate the realistic one. Let me show you another prompt. So guys, this is the prompt I have prepared. You can see dream like a beautiful girl playing the festival of color, draped in the traditional Indian, throwing the colors. Okay, now let me send and let me see the response. And if I go to the ChatGPT, see, this is the ChatGPT response. Fine. See, this is the output actually we got. Okay, it's amazing. You can see. So you can give different prompt like that, and you can generate image, and you can also control like how many images you need. So here I mentioned, I think you saw only 5 images. That's why it's giving 5 images. Okay, and you can also mention the size, everything you can mention. So yes, guys, this is the application we have developed. I hope you liked it. And now what you can do, you can improve this application. You can add some more functionality. See, I think the previous application we created, that Whishper model, what you can do, you can integrate like both application in one place. Okay, and you can create a complete platform. Okay, that thing I think you can perform. Okay, this would be a good project for you. So yes, guys, this is all about from my side. Please subscribe to the channel and share this video with your friends and family. And please support the channel, guys. If you support the channel, so definitely we'll be bringing up these kinds of content, okay, for you. And you can let us know what kinds of content you want. Okay, from my end, I'll try to provide. So I think as of now, we have worked with large language model. I have showed you the Hugging Face platform. Even we have also worked with the OpenAI platform. There we use different large language model. And whenever I was using these kinds of large language model, I think you noticed I was passing the prompt. Okay. Again, if I'm talking about ChatGPT, Google, but whatever application you can see in the field of generative AI, all the application takes the prompt as an input. Okay, based on the prompt, it will decide what kinds of output it should generate. Okay, that means prompt is everything inside large language model. Okay, whatever, let's say, large language model you are using, whatever generative model you are using, prompt is everything here. Okay, you have to give a proper prompt to get a proper answer. Otherwise, you will be getting random kinds of answer from your large language model. Okay, so that's why there is a separate concept inside generative AI called prompt engineering. Why prompt engineering? Because whenever you are writing this kinds of prompt, you have to know some technique. Okay, how we can design this prompt efficiently so that I can get the output, I can get the effective output, I can get the, let's say, useful output from my large language model. Okay, otherwise what is the use of large language model if it is giving you, let's say, random kinds of output? Fine. So that's why we'll be learning about this prompt engineering. And make sure you are watching this video till the end, because in this video we'll be covering each and everything you need to master about prompt engineering. So guys, as you can see, what is prompt engineering? Prompt engineering is nothing but prompt engineering is the process of structuring an instruction that can be interpreted and understood by a generative AI model. That means I already told you, inside generative AI, prompt is everything, and whatever prompt actually you are giving to the generative AI model or your large language model, okay, this should be well structured. Okay, this should be well structured and well organized. Okay, otherwise what will happen? Your model will give random kinds of output. Okay, that is why here I have written the definition what is prompt engineering exactly. Okay, I hope it is clear now. Now, as a generative AI engineer, you should have some responsibility whenever you will be working with the large language model, whenever you will be preparing the prompt and all. See, here I have listed down some of the points. Write, refine and optimize prompts. Perfect the interaction between humans and AI. That means you always need to make sure whether your prompt is perfect or not. Okay, to communicate between human and AI. That means you will be communicating with your AI assistant. Let's say whatever, let's say, application you are having with the help of large language model. Okay, there is a good interaction or not. Okay, the prompt actually you have given, you have to always make sure. Continuously monitor those prompts. You have to continuously monitor those prompts whether this prompt is perfect or not, and is there any change in the model or not. Then maintain and up to date the prompt. That means if, let's say, model got updated, let's say they again did the fine tune that particular model, and if, let's say, previous prompt is not working better, in that case what you can do, you can maintain and update that particular prompt for that large language model. So these are the key responsibility you should have as a generative AI engineer. Now let's try to understand why prompt engineering. Okay, so for this I'm going to show you one demo. I think this demo will give you the clear-cut idea why prompt engineering is super important if you want to work with the generative AI. So here you can see I have written a prompt. You can see this is a prompt I have written. Correct my paragraph. Today was the great day in the world for me. I went Disneyland with my mom. It could have been better if it wasn't raining. You can see some of the spelling mistake is there. That means grammatical mistakes are there in this paragraph I have written. So what I'll do, I'll give this prompt to my let's say large language model. So large language model wise here I'm going to use ChatGPT. Okay, you can also use Google Bard or any other actually, let's say, model. It's completely fine. But just to show you the demo, actually I'm going to use the ChatGPT platform. Later on, whenever let's say we'll be implementing different let's say application with the help of large language model, that time actually we'll be using this prompt with the help of Python code. Okay, as of now, just to show you the demo, I'm going to use the ChatGPT application. So guys, as you can see, I'm inside my ChatGPT. Now let's say if I give this prompt to my ChatGPT, now let's say if I send it here, see what will happen. See, it has given me straightforward results without, let's say, explaining this like paragraph I have given, without, let's say, asking me any kinds of question. It has given me straightforward answer. So here is my paragraph, and here is the correct of my paragraph, correct version of my paragraph. Today was a great day for me. I went to Disneyland with my mom, and it could have been better if it wasn't raining. Okay, you can see. So here you can see this grammatical mistake I did. It is resolved, okay, by my large language model. Now let's say you are learning about English language, you are learning about grammar, you are learning about, let's say, spelling and everything. Like that means the complete, let's say, English guidance you want, okay, from your mentor. But as a mentor wise, what you want to use the ChatGPT, let's say your large language model. That time, instead of giving this kinds of prompt to the large language model, what you can give? So instead of giving the prompt like that, you can design your own prompt in an effective way. So let me show you another example. So guys, as you can see, this is the next prompt I have designed. So here is the prompt, guys. I want you to act as a spoken English teacher. I will speak to you in English, and you will also reply to me in English to practice my spoken English. I want you to keep your reply neat, limiting the reply to 100 words. I want you to strictly correct my grammar mistakes and typos. I want you to ask me questions in your reply. Now let's start practicing. You could ask me a question first. Remember, I want you to strictly correct my grammar and mistakes, typos, and factual errors. Okay, so this is the prompt I have designed. Okay, see, previously the prompt I have given, it was like very straightforward prompt I had given, right? But now what I did, I just designed one very powerful prompt here. Now see, what should be the response from my large language model right now? So let me give this prompt to my large language model. This is the prompt, guys, the same prompt I have given. Now let me send. Now see, it is giving me great. Let's start with a question. What is the most interesting place you have ever visited, and why did you find it so fascinating? Okay, now let me give the answer. Let's say the most interesting place I visited, India, because I loved Indian food. Okay, now you can also do some grammatical mistake. Let's say here I'll just write like that. Okay, now let's say this is my response I have given to my model right now. See, my model will try to correct. First of all, you can see here is the correct version. The most interesting place I have visited in India because I loved the Indian food. Now see the reply you have given. So there actually lots of spelling mistakes were there. There are lots of actually grammatical mistakes were there. Now it has corrected everything. Now as a learner, you can easily get to know, okay, so that's how actually you have to write this particular sentence. Okay, now you don't need any kinds of actual actually English teacher. Okay, with the help of these kinds of large language model, you can easily learn these kinds of syntax. Yes or no? Fine. Now again, it is, you can see it is asking me one question. Can you tell me more about your favorite Indian dish? That means now this conversation is like more interactive. It's not like straightforward answer it is giving me. It is like more interactive. The way actually human communicate with each other. Yes or no? Now, yes, I can give another response. So here I can give, I loved chole bhature. Okay. Now let's see the output. So here is the correct version. I love chole bhature. What do you like most about chole bhature? Okay. So here I can write the puri. Now see, this is the correct version. I like the puri. What do you enjoy about the puri? Okay, now see, this conversation is more interactive. Now you can just keep on replying to the question actually this model is asking. That's actually you'll be learning about the correct, let's say, grammar, correct, let's say, spelling and all. Yes or no? Now see, with the help of just only one simple prompt design, I got like very interactive output from my large language model. Okay, this is called actually prompt engineering, and that's why it's useful. Okay, that's why it is important, because sometimes whenever you'll be creating any kinds of application, any kinds of LLM powered application, that time you have to design the prompt in such a way so that it can give the correct answer to the audience. Even it can be more interactive to the audience. That means those who are using your application, so they should enjoy your application, yes or no. So guys, that is why it's like very interesting concept, and it's like very important concept inside generative AI you have to master. Now see, to master the prompt engineering, the first thing you should know about the linguistics. Okay, what is linguistics? Linguistics is nothing but it's a study of language. That means whenever, let's say, you are studying any kinds of language, let's say English language, inside English language you are having some kinds of let's say linguistics. Okay, what kinds of linguistics you can see? Phonetics is there. So phonetics means the study of how speech sounds are produced and perceived. Okay, then there is another one called phonology, the study of sounds pattern and changes. That means whenever we are speaking any kinds of, let's say, language, like how this sounds look like, okay, how these sounds look like, how you are pronouncing this particular word and all, this is called actually phonetics and phonology. Got it. Then there is another one called morphology, the study of word structure. Then there is another one called syntax, that means the study of the sentence structure. That means whatever grammar you usually learn inside English. Then you have also having the semantics, that means the study of the linguistic meaning. Then the next one is pragmatics, the study of how language is used in the context. Then historical, the study of language change, then so on. Okay, you can see these are the actually linguistics are available to study about the language. Okay, and if you have good knowledge, on these kinds of, let's say, linguistics, definitely you can design a very good prompt for the large language model. So that is why I have written here, linguistics are the key to the prompt engineering. That means if you are having good knowledge about linguistics, definitely you can design a good prompt for the large language model. Now we have already studied about like large language model or our generative AI model, right? So there are different kinds of generative AI models are available, like GPT, BART, then Lambda, Palm, Bloom, Llama, Cloudy, okay, then Nemo LLM, okay, Generate. So these are the actually, apart from that, like there are so many large language models are available. I think I showed you one GitHub, right? I think remember Open LLM GitHub. There I think you saw thousands of large language models were there. And these are the provider and vendor, okay, like those who are created this, these are the actually large language model. See, all kinds of large language model over the internet, all the large language model accept this prompt. Okay, that means you have to give the prompt there if you want to use this kinds of large language model. Okay, because this large language model is already trained with huge amount of data, huge amount of unstructured data. Even they also did something called supervised fine tuning. They also applied something called reinforcement learning technique to improve the quality of the model. That means this model is also trained with the instruction, lots of instruction. That means they did the chat operation with this model. I think I showed you one in one video, one of my video, I already explained how ChatGPT were trained. Okay, so that's why whenever they trained with this kinds of instruction data, that means they are passing the prompt. And whenever you want to use this particular model, you also need to provide the prompt. I think now it is clear why this prompt engineering is super important. And whenever you want to use any kinds of large language model, why you have to use the prompt engineering technique. That means why you have to give the correct prompt always to the large language model. Now let's learn about some best practices to design a prompt. See, if you want to design some best prompt for the large language model, you have to keep some of the point in your mind. Let's say the first thing, clear instruction. Definitely you have to give the clear instruction to the large language model. Then adopt a persona. Then specify the format, avoid leading the answer, and limit the scope. Okay, so these are the things actually you have to always remember. Now let's open our ChatGPT and let's try to see some of the best practices, okay, we can perform whenever we're giving any kinds of prompt to the large language model. So guys, let's say if I give a prompt here, let's say I'll give when is the election. Okay, when is the election? Let's say this is my prompt. Okay, now see, if I pass this prompt to my large language model, let's see the output. It depends on which election you are referring. See, election can be vary by the country, definitely, because it's the correct one. Now you are asking what is the election, but you are not clarifying. Okay, you are not clarifying in which country you are referring. Okay, that means you have to always pass a clear prompt, okay, clear instruction to the large language model. Now see, I can give this prompt like that: when is the next president election in USA. Okay, now see, this prompt is clear and it is like well organized for my large language model. Now see, if I pass, now see, this is the answer. The next US president election is scheduled for the November 5th, 2024. Okay, now I'm getting the correct answer from my large language model. But whenever you are not giving any kinds of clear, let's say clear let's instruction to the model, it will give you unnecessary output. And again, it's a chargeable, because whenever you are using ChatGPT, or let's say any kinds of let's say commercial large language model, it is charging based on the token, input and output token. I already showed you, okay, how it will count the token and how it will charge. So whenever you are getting this kinds of unnecessary output, that means unnecessary you are spending your money, yes or no? Okay, so that's why whenever you are using this kinds of commercial large language model, make sure you have the proper prompt, so that in just one prompt you will get the actual output you are looking for. Okay, this is what actually you have to always remember. Now let me give you another example. I'll just write a code to filter out the edges from data. So let's say this is my prompt I've given. Now see, my LLM model has given me this is the output. But let's say you are looking for Java code. So you are looking for Java code, but it has given you the Python code. Again, what you have given? You have given actually uncleared instruction to the model, yes or no, right? So you have to give the clear instruction always. Now you can write this prompt like that. Write a Java code, okay, to filter out edges from the data. Now see, now it is the clear instruction to my large language model. Now I will get the Java code. Now let's see the next one, like the adopt the persona. Okay, like what is the persona exactly? Whenever you are giving any kinds of let's instruction to the model, what kinds of persona you have to adapt there. Let's say this is one prompt I'm giving to my large language model. Write a poem for a sister's high school graduation that will be read out to the to family and close friends. Okay, let's say this is my instruction I have given to my large language model. Now see, here is the response I will get. So here is the response I got. That means this is my poem. Now if you read this poem, actually this is not actually much interesting, the poem actually I was looking for. Now what you can do, you can actually give the persona. Okay, you can give the persona whenever you are giving the prompt. So now let me show you another prompt I have designed for this. So this is the prompt, guys. Now here I'm writing, write a poem as Helena. Helena is a 25 years old and amazing writer. Her writing style similar to the famous 21st century poet Rupi Kaur. So I think you know about Rupi Kaur. You can also search about Rupi Kaur. See, she is actually a Canadian poet and illustrator. Okay, you can read about her. Now see, writing as a Helena, write a poem for her 18 years old sister to celebrate her sister's high school graduation. This will be read out to the friends and family at the gathering. Okay, now see, this is the prompt actually I've given. Now see, if I send it, if I send this prompt right now, now see the response actually I got here. Now if you read this poem, actually it is too good. It is too good than my previous response I got. Okay, so that's how actually you have to adapt the persona always. You have to adapt the persona, what kinds of things you are looking for. Now see, this large language model is already know about Rupi Kaur, okay, because it is already trained. It is already trained, let's say around 2022 data. Okay, till 2022 data it has already trained, and in that data actually Rupi Kaur poem was there. Okay, that's why you all that's why this model is already known about Rupi Kaur, and it is trying to get the similar kinds of, let's say, poetry. Okay, whatever, let's say, poem actually Rupi Kaur used to write. Okay, the same actually syntax context actually it is trying to, let's say, gain. Now the next thing, you can also specify the format. Let's say what kinds of format you want as a output. Let's say what I will go, I will give you one example for the summarization. Let's copy one English story here. So let's say this is one English story. I'll just try to copy the entire story. And here I'll go to my ChatGPT and I'll just write, please summarize this story. Okay, summarize this story. Now I can pass the entire story here. Now see, I can send it. Now see, it is giving me the summary, but see, this summary again, it's a paragraph. Okay, it's a paragraph. Now I can also specify the format. Let's say I'll give, I want, I think I can copy the same instruction. Now here, just try to modify. Please summarize this story in bullet point. Okay, bullet point. Now see, I'm specifying the format. Now see, if I pass this, now see, it will give me inside a bullet point. Okay, now see, it's like more readable. Nah, it's more readable. It is giving me some actually important actually summary of this entire story. It is trying to return me. Okay, so that's how you can provide any kinds of format you need. Let's say you need a data and you need a JSON format data. You can also provide, I need a JSON format data. Okay, you can pass the prompt and it will give you that. So that's how actually whenever you are designing your prompt, you have to always keep these are the point in your mind. Okay, the point actually I listed down in my presentation. I think you saw that, right? Now there are some types of prompt are available. So the first type you can consider zero shot prompting, and the second type actually few shot prompting. Apart from that, actually there are like some types of prompts are available like emotional prompting and all, right? But this is not actually required. But if you want to create any large language powered application, so this two prompt actually very famous. So I have seen like people are using this to prompt a lot, like few shot prompting and zero shot prompting. So let's explore this zero shot and few shot prompting in the example. So again, I will go to my ChatGPT. Now, first of all, let's write the zero shot prompting. Zero shot prompting means you are only asking the instruction, because see, this ChatGPT is already trained with huge amount of data. So this ChatGPT has already like lots of knowledge about, let's say, the data over the whatever data they have trained. Now let's say I will ask one question: when is the Christmas in America? Now see, Christmas in United States celebrated on December 25th each year. Okay, now it is giving me the answer. So this is called actually zero shot prompting. That means you have only give one prompt. Okay, one prompt, that means the instruction you have given, the question you have given. Okay, but let's say if I ask these kinds of question, now let's say if I ask this kinds of question, what is Bappi's favorite types of food? Okay, let's say this is the question I have given. Now say it will give you, I don't have the information about Bappi favorite types of food. Could you please provide more details, clarify who is Bappi? Okay, now see here actually zero shot prompting is not working. So here you have to pass the few shot prompting that time. Okay, now see here I'll give a prompt. Now I'll just write Bappi is a data scientist and his favorite types of food are, or you can write food includes, let's say, burgers, pizza, okay, and chicken. Now I can pass this prompt to my large language model. Now it will learn about me. Okay, because I have given a few short prompt here. Okay, now see, got it. Bappi favorite types of foods are burger, pizza, chicken. And if you need any more details or have a questions, just let me know. Now here I can give another prompt. What is the, or I can write what restaurant. Now let's say this is the prompt I have given. What restaurant should I take Bappi to in Dubai this weekend? Okay, now see if I pass. Now see, it will suggest me some restaurant. Dubai has fantastic range of restaurant that caters a variety of tastes, since Bappi like burgers, pizza and chicken. Here is the few recommendations. So here is the restaurant. Now see, this is called actually few shot prompting. That means you are also giving some few shot prompt. That means some let's say information about the question you are asking. Okay, this is called actually few shot prompting. So these are the things, guys, you have to master. So see, this prompt engineering will come automatically whenever you will be writing these kinds of prompt. So unless and until you are not writing, you are not experimenting, you won't be able to understand, okay, which prompt will give you what kinds of output. So try to practice a lot. Okay, you have the ChatGPT, you can give different prompts and you can get the response from the ChatGPT. And the prompt actually you are giving to the ChatGPT, the same prompt you can use to any kinds of large language model. Okay, in future you will be using, whether it's a let's say Gemini, whether it's a let's say Mistral, Falcon, whatever let's say your model you are using, you can use it as it is. Fine. Now there is another concept inside actually generative AI model called AI hallucination. Now what is an AI hallucination? See, AI hallucination is when a large language model generates false information. That means let's say you are giving a prompt and that model is giving you the false information. Okay, so this is called actually AI hallucination. That means the prompt you are asking, the information you are asking, this information is not available to the large language model. Okay, so that time what we have to do, if we are getting this kinds of hallucination, so that time we can use something called RAG concept. That means retrieval augmented generation. That means we can connect our external data source to my large language model. Okay, and from that data sources my model can learn, okay, this is the information you are looking for. And if RAG is not working, that time what we can perform? We can perform something called fine tuning of a large language model. I think I showed you. Now we can perform fine tuning with the help of Hugging Face. Okay, so I'll also show you how we can fine tune different kinds of large language model on top of our custom data. We can also perform fine tune operation. But fine tune is a costly task because here you need a good system, like lots of data. Okay, so again, it's like very costly task. But RAG application is a very easy kinds of task. See, here you don't need lots of cost. Here you don't need lots of computational power. Okay, so both will be exploring one by one, like what is RAG concept and what is, let's say, fine tuning concept. Everything will be exploring. Okay, so yes, guys, this is all about our prompt engineering. Now I think you got it why prompt engineering is super important and how you can master this kinds of prompt engineering technique. Okay, it's nothing but it's just a way of, let's say, communicating with your large language model. The input you are giving to the large language model, this is called actually prompt. Okay, and the way you are designing this particular prompt, this is called prompt engineering. Okay, I hope it is clear now. See, if you want to learn, if you want to master generative AI, if you want to work with the large language model, so this is super important concept you have to first of all master. And this is called actually vector database, because see, whatever, let's say, data you will be using, whatever documents you will be using, let's say, to work with your large language model. So first of all, what you have to do, you have to convert the documents to the embedding representation. I think I already explained like what is embeddings, right? So my model can't take the English input directly. So for this, I have to create some number. Okay, that means I have to generate the embeddings, I have to generate some vector. And after generating these kinds of embedding and vector, we have to store these are the vector to a databases. Because I have to connect my large language model with these kinds of databases. Okay, so this is called actually vector databases. Okay, I hope it is clear now. So no need to worry, I will give you the entire idea of this vector database, like what vector database is. Even I will also show you the different practical with different vector databases. So here we'll be covering almost all the famous vector databases, whatever, let's say, people are using broadly in the market. We'll be covering all of them, no need to worry. And guys, to show you this vector database demo, I'll be using one framework called Langchain. So Langchain is a generative AI framework. With the help of Langchain, actually, we can build different generative AI based application. Because inside Langchain, actually, all kinds of vector database functionality are already available. Okay, so that's why I'm going to use Langchain throughout the entire, let's say, a series of this vector database. But if you're not familiar with Langchain, no need to worry. Go through this tutorial and try to implement whatever things I'm implementing. So after this vector database series, I will start the complete Langchain series as well. So there actually will be starting from very basics of the Langchain, even we'll be covering till advanced part of the Langchain. Okay, we'll be learning each and everything. As of now, let's say as a code wise, just try to understand, okay, what are the functionality actually I'm using from the Langchain and try to implement with me. And make sure whenever I'll be installing any kinds of package on my Collab notebook, try to see the version. Okay, try to see the version of that package, because today actually I'm creating the video. I know that because this is a completely research field. So some of the functionality they will change in their package, and then you will get some issue. Okay, you might get some issue, you might get some error. So make sure whatever, let's say, version I'm installing on my notebook, try to also install the same version. And if I'm not mentioning the version, okay, with the package, what you can do, so whenever I will show you the installation, below in the console you will see the version. Okay, like what is the Langchain version, what is the OpenAI version, what is the, let's say, vector database version. Okay, just try to see the version, try to just note it down and try to install the same version. It will work, because see, it's a completely research field. Every day they are updating their package and all. So I know that if you're learning something today, so tomorrow actually they will update that package and you might get some issue. Okay, so that's why I'm telling you guys, always try to use one specific version. Okay, if you're using a specific version, so you won't be having any kinds of issue, because you know that this version will work fine. Okay, the code you have implemented. So that's why just try to see the version, whatever version I'm installing. See the console of that Collab notebook. There actually will see all the version has been written, okay, for all the package. So note it down and try to install the same version. Now let's try to see what are the topic actually will be covering through this vector database series. So guys, as you can see here, first of all, we'll be learning about vector database, like the in detail explanation of the vector database, what is vector database, how it is work and all, everything we'll be learning. Then we'll see that why we need the vector database, how vector database works, use cases of the vector database, then some widely used vector database will be also learning. Then at the last of the series, actually we'll be also doing the practical demo with the help of Python and Langchain. As I already told you, we'll be using Langchain framework to work with the vector database. Okay, now let's try to see what is vector database is. See, vector database is nothing but a vector database is a database used for storing high dimensional vectors such as word embeddings or image embeddings. So I think you already know that we are having lots of unstructured data and higher dimensional data like documents, image, PDF. Okay, then we are also having audios, videos, and so on, right? So this is called actually unstructured high dimensional data. So what we have to do inside vector database concept, we just need to first of all convert these are the higher dimensional documents to the higher dimensional vector. You can see we are converting these documents to a vector representation, and this vector actually we are storing to the database, and this is called actually vector database. Okay, that is why here I have written a vector database is a database used for storing high dimensional vectors such as word embeddings as well as the image embeddings, because I think you already know that inside generative AI we are having textual data as well as the image kinds of data, that means video data, audio data, and so on, right? So that is why you can consider any kinds of data, and whenever you're considering any kinds of data, it will have some embeddings, and that particular embedding you have to save to the vector database. So this is the introduction of vector database. I think it is clear. Now you can ask me like why we need this kinds of vector database, because we have lots of existing database are available in the market. Now to give you the answer, actually I want to show you one example. So first of all, let's see like why we need this kinds of vector database. Because if you see over like 80 to 85% data out there is unstructured data. Like we have images, we have videos, we have text, and we have audios. Okay, so these are the data, actually unstructured data. So we can't easily store these kinds of unstructured data to the relational database, or let's say our traditional database. Like we have MySQL, then we have PostgreSQL, then we have SQLite. So these are actually relational database, and these are actually traditional database. So we can't directly store, these are the data. So we can directly store our unstructured data to these kinds of relational or traditional database. Okay, why we can't store? I will show you one example. It would be very much clear. So guys, to give you one example, let's take one image data as an example. So let's say I want to store these kinds of dog images to our relational or our traditional database. So if I want to store it, I can't directly store these are the data to our relational database. Okay. So if I want to store it, so what I need to do, I need to create some of the schema. Let's say I have some schema here. I have some table. So in this table, let's say I have one column called animal. Okay, animal. Then I have another column called color. Okay, then I have another column called tags. So basically you need to manually label them to store these are the images. Okay, if you want to identify similar kinds of images, if you want to apply the query on top of that, then you need to create these kinds of schema manually. Now here you just need to set those parameter manually. Let's say animal wise it's a dog. Okay, it's a dog. Then color wise, let's say it's black, or let's say I can, and color wise you can give any color, let's say golden. Okay, this is the golden dog, golden dog. Then we have, let's say, black dog as well. Okay, black dog, you can give anything based on your image actually you are trying to store. Then you also need to assign some of the tags. Let's say this is very cute. Let's say this dog has black eyes. Okay, black eyes. So these are the tags actually we'll be assigning manually. So what happens actually, so whenever you assign these kinds of schema manually, so what happens, let's say you want to query the similar images, okay, from the database. So you just give these are the parameters, so it will return these are the image for you, okay, based on the tags actually you have written, based on the schema you have prepared, right? But again, it's a manual thing. Okay, it's not an efficient way to store our data, and it's not an efficient way to like query out our data, because let's say I want similar kinds of image, so I need to assign these are the labels manually, and it's like very hard task for us, right? So that's why actually we can't use our traditional, or let's say relational database for these kinds of unstructured data. We can easily use these kinds of relational database for the structured data. Let's say we have CSV data, we have Excel data, but for these kinds of unstructured data, it's like very much difficult to store these kinds of data, right? You can store them, there is no issue, but the thing is like whenever you will be querying out from your database, let's say you want similar kinds of dog images, at the time it would be very much difficult, because if I, let's say, convert this image to base64 string, so using base64 string I can easily store the data to the relational database. But I'm talking about whenever, let's say, you are applying query on top of that, let's say you want similar kinds of dog images from this database, at that time it would be very much difficult for you to querying out, because it doesn't know like whether this base64 string is a dog image, or let's say it's a cat image, or let's say it's a horse image. Okay, it doesn't know. So there is only one option to filter out these kinds of images. The thing is like you need to create one manual schema, like these kinds of tags you need to generate, you need to label out these are the images. Using that actually you can filter out these kinds of data, but again it would be very hard approach, as I already told you, because you need to apply manual observation here. Now guys, I think you already got the idea like why it is difficult to store these kinds of unstructured data to the relational database, because as you can see, image is nothing but it's a pixel, and your relational database doesn't ever know like how to query out similar kinds of images using these kinds of pixel, right? So guys, this is the one major problem with these kinds of relational database whenever we are using unstructured kinds of data.
So guys, whenever I'm talking about unstructured data, it is not only image data. So it can be video data, it can be text data, and it can be audio data as well. So guys, to overcome this issue, there is a concept introduced called vector embedding. So let's say we have unstructured data. Let's say we have image, we have text, and we have audios, and it can be also videos. So first of all, what we need to do, we need to apply something called embedding model. Okay. So embedding model is nothing but it's a neural network based model. It's a deep learning model. So using this embedding model, first of all, you will be generating some of the embeddings, or let's say vectors. Okay. Let's say this is my image. We have applied embedding model. Embedding model will give you vectors. Okay, like this is the representation of the image. Okay, this is the numerical representation of this image. It can be also applied to the text data. So you see here I'm giving the text data, and this is my embedding model, and it is returning this kinds of vector. Again, you can also put audio data, so it will convert to the numerical representation, and this is the representation of the audio. So here if you see, embedding model is nothing but it's a neural network based model. Here you can use any kinds of embedding model. Let's say we have what to wake, then we have transformer based embedding model as well, right? So these are the things actually you can use. So if you're already familiar with NLP, that means natural language processing, I think you have heard of like what to wake, then you have heard of like transformer embeddings. Okay, and nowadays actually we have large language model based embeddings, like we have OpenAI embeddings, we have lots of open source LLM based embeddings as well. We have Hugging Face embeddings as well. So using these kinds of embedding model, we can easily generate these kinds of vectors, and we can store them in a vector database. So guys, this is the entire idea on top of this unstructured data, like how we can store these kinds of unstructured data to the vector database. So first of all, what we are doing, we are just trying to convert these are the unstructured data to the vectors, vector representation. Then we are storing these are the vectors, okay, to the vector database. So guys, here is an example you can see. So let's say we have text unstructured data, and here you can use any kinds of embedding model. So in this case, actually, I have referred this OpenAI embedding model. So it is already trained on GPT model, okay, GPT-3 and 4 model. And if you put these kinds of unstructured data to the embedding model, it will give you these kinds of vector, okay, these kinds of vector representation of all the text actually you have in the documents. Then once you got this vector, actually this vector embedding, then you will be using some vector database. It can be anything, any database you can use. So here you can store one by one, these are the data. Okay, so this is the complete idea of this vector database. Like instead of directly storing our text data to the database, first of all, what we are doing, we are taking help from the embedding model, and using the embedding model, we are trying to generating these kinds of vector embeddings. Then we are storing these kinds of vector embeddings to the vector database. And guys, this kinds of vector database has one beautiful function called similarity search. So using this similarity search functionality, it can return you similar kinds of vector represented in the vector database. Okay, I will show you this similarity search as an example, like how it is doing actually similarity search. Now guys, you got to know like what is embedding, but you don't know like how these embeddings are generated. So to give you one example, I will open my whiteboard, and there I will try to make you understand. So guys, I'm inside my whiteboard, and here first of all what I will do, I will take one pen, and here I'll be using unstructured data, unstructured data as text data. Here I'll be using text data to give you the example. So first of all, what I will do, let's create one table here. So let me create one table. So guys, let's say I have taken one table here. So here we are using one embedding model. So let's say we are using one embedding model to convert our text to numbers. So here you can use any kinds of embedding model. You can use OpenAI based, you can use what to wake, you can use large language model based, you can use anything here. Okay, now whenever let's say I have some words here. So let's say I have something called king, then I have something called queen, then I have something called man, and I have something called woman, then I have some let's say monkey. So let's say I have 5 words here. Now what this embedding model will do, it will try to generate some of the features on top of the words. Okay, let's say this is my featured column, features column. Okay, so what kinds of features actually it will generate? Let's say it can generate anything. Let's say it can generate gender, it can generate wealth, it can generate power. Because this is a neural network based model, we can't say like what are the features actually it will generate, because it will generate these are the features based on the back propagation. So it will calculate the loss and all. Based on that, actually it will try to find out the best possible features, okay, for these kinds of work. So here I'm just giving one example, that's why I'm taking these are the features, okay, but it might not like generate these are the features, but to give you one example I will be using these are the features. Now let's say it will generate weight, and it can also generate something called speak, okay. Now what happens actually, based on the features, actually it will assign some of the value. Let's say here my first word is king, okay. Now king has gender or not? Yeah, king has gender, and the gender is like male, so it would be 1. And for queen, yeah, queen has also gender, so it would be 0 because queen is a female. So similar wise, man has a gender, so it will have 1. And woman also has gender, so it would be 0 because it's a female. And monkey, let's say it's a male monkey, so I'll assign it 1, okay. Now it will come to the next features called wealth, okay. Now here you can see king has wealth, right, because he's the king and he has lots of wealth, so it would be, let's say 1. I'll assign it as 1. Queen will also have wealth because queen is also part of king. And man will also have wealth, but it would be less than king and queen, so let's assign as 0.5. And women will have also wealth but less than man, so here I can give 0.3. Monkey doesn't have any wealth, so I'll give as 0, okay. Now king has power, so I'll give 1. Queen has also power but less than king, so I'll give 0.7. Man has also power, let's say man has power but it's less than king, so I'll give as 0.5. Woman has also power but it's less than man, so it would be 0.2. And monkey doesn't have any power, so I'll give as 0. Now weight, yeah, king has also weight, so I'll give 0.8. And let's say king is a little bit obese. Queen has also weight, so I'll give as 0.5 because let's say queen is slim and all. Man has also weight, so I'll give it as 0.7. Women has also wealth, I'll give 0.5. Weight is fine, I think. Monkey also has weight, let's say 0.3. Now king can speak, so I'll give 1. Queen can also speak, I'll give 1. Man can also speak, I will give 1. Women can also speak, I'll give 1. And monkey doesn't speak, okay, so I'll give as 0, okay. Now see guys, beautifully it has generated these are the vectors, okay. By generating these are the features. Now let's say if I want to represent king, okay, if I want to represent king, so what would be my king vector? So here this is your king vector, so king vector is nothing but 1 1 1 0.8 1. So this is the king vector. Now if I want to represent queen, so this is my queen vector, so queen vector would be 0 1, then 0.7 0.5 and 1, okay. Now if I want to represent man, so this is the man vector, so 1 0.5 0.7 and 1, okay. Now let's say if I want to represent women, okay, I think you are getting it, like how we have generated these are the vector. Now this is the vector of the women, so 0 0.3 0 0.3 and 0.2 0.5 and 1, okay. Now let's take one 2D dimension, okay, and plot these are the vector and try to understand like what will happen. So let's say here I will take one 2-dimensional space. So let's say this is my 2-dimensional space, okay. So this is my x and this is my y. So if you plot all the vector here, okay, if you plot all the vector here, you will see king and queen, king and queen will appear to the similar. So here let's say this is my king and this is my queen, okay. So what will happen whenever you will plot these at the vector to the 2-dimensional space, or let's say 3-dimensional or any dimension, okay, you will see king and queen will appear like very close together, because if you see here, okay, if you see here, as per the features, if you calculate the number, if you calculate a distance between these are the vector, you will see this distance would be like very less, okay. That's why king and queen would be appearing very closely together. And here man and woman, let's say this is my man vector and this is my woman, okay, this is my woman. So these two vector would be appearing closely. And here, if you see here, there is another vector called monkey. Okay, monkey will appear completely different from these are the vector, because monkey is a different entity here. So let's say this is my monkey. Okay, now if I show you, see, so it has built one cluster. So this is one cluster, this is another cluster, and this is another cluster. Okay, now if you see here, using this concept called vector embeddings, uh, we are easily getting these are the similarity score. Okay, similarity vector. So now if I want to extract any kinds of vector, okay, let's say I want queen. Okay, I want queen, so it will go to this cluster and will return this vector. And let's say not only queen, let's say it would be, let's say I want something called princess. Okay, I want something called princess vector. So what will happen, it will come in this cluster, because if you calculate the vectors, okay, of the princess, you will see it will have these are the features. Okay, it will have these are the features related to the king and queen. Okay, so now this princess will appear here. So that's how actually this embedding model works actually. So it will first of all assign some of the features, based on that it will generate these are the vectors, and it will plot these are the vectors to the higher dimensional space. So here in this case I have taken 2-dimensional space, but it might be 3, 4, 5 and so on. Okay, based on your dimension of the data. So whenever I'm using unstructured data, whenever I'm using real world data, so dimension might be vary. Okay, it might be millions dimension, it might be 1,000 dimension. We can't say like what are the dimension it will have, but as a visualization we can only show 2D space here. Okay, so this is the complete idea, guys. I think you got it, like how these embeddings model are working. Okay, and how it is generating these kinds of vector. Okay, now here in this case actually you have lots of embedding models. So we have OpenAI embedding model, and this model is trained on GPT. Okay, GPT model, I think you have heard of GPT model. Then we have something called Hugging Face embedding as well. Okay, Hugging Face embedding. So it is already trained on, let's say, lots of open source LLM. Okay, that means large language model. Then we also have something called Llama. Okay, Llama 2 embedding. I'll be discussing like what is Llama 2 and all. Okay, as a open source model. Then we have something called Google Palm embedding. So these are the open source embedding you can directly use. So this is from Facebook research. Okay, and this is from Google research. Okay, and this one is paid, because if you are using OpenAI embedding and OpenAI model, so you need to pay. This is completely paid, and these are the things are free. Okay, these are the things are open source and free. But to get the Llama 2 access, actually you need to like send some information, then they will give you the access. I'll tell you like how to take this Llama 2 access and all. Okay, everything I'll be discussing about. Don't worry about, like, just try to stay with the video. I'll be discussing each and everything. So guys, I hope you got the entire idea, like how these embeddings models works. Okay, and how it generate these kinds of embeddings as a vector, right? So guys, here I kept another example. If you just see this example, your concept will be very much clear. See here, I have these kinds of words, okay, and we are using these kinds of embedding model, and we are generating these kinds of vectors. And if we plot these are the vectors to the 2D dimension, so it will look like that. So let's say we have this 3 word, we have this 3 word, and we have this 3 word, and we are getting different vector. And this is the cluster. Okay, this is the cluster of each of the words. If you see here, king, man, women, it's appearing in the same cluster. Then apple, banana, orange is appearing to the another cluster, and football, golf and tennis, it's appearing in the another cluster, because this is related to a person. Okay, person, and this is related to fruits, and this is related to sports. Okay, that's why this cluster is different. Now I think you got it, them vector embeddings, like how this vector embeddings looks like and how it is generating. Okay, I have given you the entire idea. But one issue actually with this vector embeddings, which is nothing but whenever you are getting any similar kinds of vector, it is applying something called distance formula. I think you have heard of like distance formula. We have Euclidean distance. Okay, we have Manhattan distance, or let's say we have something called cosine similarity score as well. Okay, so using these are the equation, actually it try to calculate the similar kinds of vector. But again, if you see here, it would be very much time taking, because it will calculate with respect to one by one all the vector, then it will give you the similar kinds of vector. So the main problem is like the time. If you're using this thing directly, so it will take lots of time to give you the similar kinds of vector. So to overcome this issue, actually they propose something called indexes in the vector database. Okay, like we call it as vector indexes. So what is vector indexes? So let's say whenever we are having these kinds of unstructured data, we are applying this kinds of embedding model, and it is generating these kinds of embedding. Okay, so on top of this embedding, where what is trying to do, it is trying to add some kinds of indexes. Okay, so this indexes is nothing but it's a data structure. It's one kind of data structure actually. So what it will do, it will find out similar kinds of vector and it will assign some of the indexes. Okay, and it will make some cluster kinds of thing. So whenever let's say you have any new data, first of all it will see like which indexes actually it lies this data. So in that index only it will search that query. So to understand this, let's say this is my example. So first of all, let's say it has assigned these kinds of indexes. Now you have one new data. Now first of all it will see like which cluster actually this is lies. Okay, so it will go to that cluster, then it will return the similar kinds of vector with respect to the new data you are giving. Okay, instead of searching to all of the clusters. So this is the idea of these indexes in this vector database. Now using these indexes to our vector database, it's like very fast. Now whenever you are asking any kinds of query to the vector database and it is returning any kinds of vector, so this process time would be very fast. Now guys, I hope you got the entire idea like what is a vector database and all about, and what is embeddings and all about. Now you can tell a vector database indexes and store vector embeddings for faster retrieval and similarity search. So we used to use our traditional database to directly store our data, but in the vector database, first of all, we try to convert as vector, then we try to store them to the vector database. Okay, this is the complete idea. Now guys, let's discuss some use cases like why this vector database is useful, like what are the use cases are there. So as you can see, it will help you the long term memory for the large language model, because it is storing all of the data as a vector to the vector database. So whenever you are connecting these kinds of large language model to the vector database, so it can be used as a memory. Okay, memory of your large language model, like long term memory. And it can also perform something called semantic search. I already told you how to perform the semantic search using the formula and using the indexes and all. So search based on the meaning of the context. Let's say if you're giving something called, let's say, king and queen, so it will not only consider the text you are giving, it will also consider the context, like what is king, what are the features of king, what is the features of queen. Based on that, it will give you the similar kinds of vector, okay, as a output. Then it can also perform something called similarity search, as I already told you, like on the text data, image data, video data, or let's say audio data. Let's say I have one image, let's say dog image. I will tell hey, just give me some dog images, okay, similar kinds of dog images. So it will first of all try to see the vector, okay, similar kinds of vector, and it will return the similar kinds of representation of the dog to you. Okay, so we call it as similarity search. Then it can be also used in the field of recommendation system, because as you already saw, like if you are having these kinds of vector together, and it can perform similarity search. Let's say I want to build something called recommendation system. So let's say I'm asking for like food related content, so it will suggest me food related content only, okay, using these kinds of similarity search and all. So guys, this is the entire idea of this vector database, and these are the use cases actually you can consider, okay, inside this vector database.
So guys, I think so far everything is clear. Now let's try to see some widely used vector database. So you can see we are having ChromaDB, Weaviate, then Fias. So Fias is implemented by Facebook AI. Then we are also having Pinecone, then Neo4j. Neo4j is a graph-based vector database. Okay, so these are the actually very common vector database people are using in the market, and it's like very famous vector database, okay, in the market right now. So here we'll be exploring all of them one by one. So in the next video, we'll try to see how we can use ChromaDB, and ChromaDB is a local vector database, and this Pinecone, Weaviate, Neo4j, it's a cloud-based vector database. Okay, and here is another vector database. You can see Fias. Fias is also a local vector database. That means if you want to, let's say, store your data as a locally, so what you can do, you can use ChromaDB or Fias. And if you want to store them in the cloud, you can use Pinecone, Weaviate, or Neo4j. Okay, now in this video, actually, we'll start with one practical demo. That means we'll be learning one amazing vector database, local vector database called ChromaDB. You can see ChromaDB is a local vector database. So they're also bringing the hosted version of the ChromaDB. So you can see it is still under development. So once it is done, you will be also able to, let's say, use this ChromaDB in the cloud server as well. So as of now, if you want to store your, let's say, embeddings in the local, okay, that means if you want to set up everything in the local, you can use ChromaDB vector database for this. So this is the documentation of ChromaDB, guys. You can see this is the official documentation. So they have given each and every guideline. So you can follow this documentation, like how we can set up and all. Okay. So what I will show you guys, I will show you one complete practical. That means we'll be experimenting this ChromaDB on the Colab notebook. Okay. So guys, let's open up my Colab notebook and let's see how we can use this ChromaDB vector database. So guys, as you can see, my notebook is connected. Now, if you want to test it, whether it's working or not, just write one message here. So I'll just write print. Okay. So it should, yeah. So it's working fine. Okay. So now the first thing, I'll be installing some of the like required packages. Like I need to install the ChromaDB and all. So there is the guide actually. They have given like you need to use pip to install the ChromaDB and how to like set the client and all, everything they have given. Okay. So first of all, what I will do, I will just set up this ChromaDB. So to set up the ChromaDB, you will need some more required package. Okay. Some more dependency. I'll tell you like what are things you need. So just write pip -q install. First of all, I need something called ChromaDB. So I'll copy the name from here. ChromaDB. Then I need something called OpenAI, because I'm going to use OpenAI embeddings and OpenAI, like you can say LLM model. Okay, that means GPT 3.5 turbo model. So that's why I need OpenAI. And I also need something called Langchain, because I told you I'll be using Langchain here. Langchain, and there is another dependency you need, something called tick token. Okay, tick token. So if you are using OpenAI embedding, so you need this package actually, tick token. Now, yeah, I think these are the things actually I need. Now let me install it. And guys, you need OpenAI account for this video actually. So just try to create an account here. Otherwise, you won't be able to do it because you need the OpenAI API key, okay, to run this, like you can say notebook. So guys, installation is done. Now, if you want to see, let's say any version of any package, so what you can do, let's say I want to see the ChromaDB version. So I'll just copy the name, and here you can just write pip show, pip show, and just give the name of the package. Now, if you execute, it will show you the version and every information about this package. See guys, name is ChromaDB, and this is the specific version, and this is the entire summary of your like ChromaDB package. Okay, so that's how you can see for all the packages, okay, you have installed. Now here, first of all, I need to download some data. Because here I'm showing you vector database example, and there actually I need the data, okay, to show you like how to store and all. So for this actually what I will do, so there is a actually this Dropbox links, actually you can see this is the Dropbox links, and inside that actually you have some article data. If you see, Google article is there, then you have some AI startup article, Amazon article, then you have Databricks article, ChatGPT article. So we have different articles here, okay, and this is a txt data, txt format data. Now if I open any kinds of txt file, see this is the article related to this default, okay, generative AI. So they have written all the article and all, okay. So I'll be using these kinds of data. You can use any kinds of data, it's up to you, but this is the open source data actually I got from the internet, and this is the link of the data. So to download this data, first of all I will copy this link, and here I'll be using something called wget to download this data. So I'll just write wget. So wget is a Linux command, and here we are using Google Colab, and Google Colab is running on the Linux operating system. Okay, so it is running on the Linux kernel. So that's why you can execute any kinds of Linux command here. So here I'll just write wget -q, and here I'll just paste this link. Okay, I'll paste this entire link. Now once it will download, let me show you how it will download. So if I execute this cell, left hand side you will see it will download that zip file. Okay, see new article.zip file, this zip file has been downloaded. Now I also need to unzip this zip file, so I'll just write unzip -q, and this is the name. I'll just copy the name. I'll just copy the name, and here I'll just tell the directory like where you need to I mean unzip it. So I'll give the same name. So
This is the name, new underscore articles. Okay, so it will create one folder, new underscore articles, and inside that it will unzip everything. Okay, now if I show you, it's done. Now if I refresh the page, I think inside new articles, now see guys, all the articles are present. Okay, now let's see if you want to open it, you can also open and see. So this is the article and all about. So now let me close this thing. So we have successfully downloaded our data. Now what I need to do, I need to first of all create one OpenAI API key, and I'll be setting up my environment. Okay, so for this actually what I need to do, I'll first of all open up my OpenAI account. So you just also open up your OpenAI account. Just says just search like openai.com, and here just try to log in with your account. So let me quickly log in with my account. So guys, as you can see, this is my account. Now here I'll just click on this personal, my this is my profile. I'll click here, and here you will get one option called view API keys. Okay, now I'll click here, and here you will see API keys option. Okay, now see, previously I created some of the API keys, that's why you can see here, but for you it might be completely empty. It's completely fine. So you'll get one option called create a new secret key. Okay, just click here and just give the name. So in this case I'm using vector.db. So vector.db, I'll just name it. Okay, you can give any name. I'm just giving vector.db and create the keys. Now you need to solve one puzzle here. It will verify whether it's whether you are a human or not. Okay, so I'll just click here. Now it's telling just try to move this object with respect to this hand direction. So let me move it and submit. I think yeah, attempt is complete. Now I will get my secret key. Yeah, now I'll copy this key, and here I'll paste it. Okay, as of now I'll paste it, and I'll just give a comment here, setting up setting up environment. And don't share this key with anyone guys, otherwise they will also able to access your like you can say OpenAI account. I will be removing these keys after this recording, so that's why I'm showing. Now here first of all I will import operating system package called OS, and here I'll set the environment. So I'll just write OS dot environment environ. Okay, and here you just need to give the keys, like which name you need to save it. So I'll just give OpenAI underscore API underscore key, and equal to, I'll set my API key here. So this is my API key. I'll copy, or I'll cut it, and here I'll set it. Yeah, that's it. Okay, now I can remove this cell. Now let me execute. Done. Now I need to import some of the necessary libraries. So import. So first of all, I need to import something called Chroma. Okay. So if you're using Langchain, so Langchain already has this Chroma API, because I already told you the integration. So it is the integration with the Langchain as well as the LlamaIndex. So instead of like importing directly, like import Chroma, okay, import Chroma, we have to import it like from the Langchain itself, because here I'm going to use Langchain framework, okay, to build my application. That's why I need to call it from the Langchain. But let's say if you're using it for any other like task purpose, let's say you are not creating any generative AI application, let's say you are doing some different thing, okay, different application, at that time you can directly import it, and all the functionality will remain same only, all the code will remain same only, you just need to change the import, okay, at that time. So here I'll be using Langchain, so I need to import it from the Langchain itself. So how to import it? So just write from Langchain dot vector store. So there is a function you will get called vector stores import. So I'll import my Chroma. So I'll just write Chroma. Then I also need to import OpenAI embedding, because I think you remember. Let me open my board. I think you remember, first of all, what I need to do. Let's say I have my unstructured data. So let's say this is my data. So the first place what I need to do, I need to use something called embedding model. Embedding. model. So this model might be anything. So in this case, I'm going to use OpenAI embedding model. OpenAI embedding model I'll be using. So you can use any model here. Okay. Then after that, it will return me my vector embedding. Vector embeddings. Okay. And that vector embeddings I will store inside my vector database. Okay. Vector DB. So in this case, I will be using something called ChromaDB. ChromaDB. Okay, so this is the complete idea. So first of all, I need to import this embedding model as well. So here I'm going to use OpenAI embedding, so I can directly import OpenAI embedding. So let me do it. So here I'll just write from Langchain dot embeddings import OpenAI embeddings. OpenAI embeddings. Okay. Then I also need to import OpenAI because I'm going to use OpenAI large language model. So again, I'll just write from Langchain dot LLMs. That means large language model. I need OpenAI. Then I need to load my data. As you can see, this is my data and it is present inside a directory. Okay. And again, this data format is a TXT data. Okay. If you see, it's a TXT data. So for this, I again need two libraries. So I'll just write from Langchain. So guys, I'm expecting you are already familiar with this Langchain because if you check our YouTube channel, so we have already covered this Langchain tutorial and all. Okay. So you can go with that tutorial and you can learn the Langchain. So here from Langchain, there is a class called document loader. So just write document loaders. Okay. So first of all, I'll be import something called directory loader. Okay. Directory loader. Because my data set is present inside the directory. That's why I need this directory loader. Then I also need to load my text loader because it's a TXT data, right? So I'll import the same thing only. Sorry, it should be data loader, I think. Document loader. Document. It's a document loader. Okay. Now it should be text loader. Text loader. Okay. Yes. So as of now, I need these are the libraries, and if I need anything, I will be importing later on. So let me just quickly import them. Now we'll be loading the documents. So load data. So guys, to load the data, just write directory loader, and inside that you just need to mention the directory. So here this is the directory. I'll just copy the name, copy path, and I can give it here. So this is the directory, and inside that actually I have txt data. Okay, I have, if you see, I have txt data. So I only want to load the txt file. So if I, let's say I have some any other file, okay, I will be ignoring. So for this, there is a parameter you can give called globe. Okay, just write globe equal to, so it should be txt file. So all the file just load. Star means all the file. Okay, it should be dot txt. Then you also need to define the loader class. Okay, so just write loader class, and should be my text loader because all the file are txt format. Okay, that's why you need to give this text loader. Okay, now it will load up your data, and I'll be storing this data inside a variable called loader. So this is my object of my data loader. Now let me execute it. Now to load the data, you need to call one function called loader.load. Okay, if you call this function, it will load the data, and this data will store it in a variable called document. Okay, and see guys, it will load all the data inside this document. See guys, this is the all of the text actually you can see here. So it has loaded all the txt file one by one, and it has extracted the data, and this is your entire data, as you can see. So let me show you. See guys, and this is a document object. Okay, this is a document object. Now we have successfully loaded our data. Now guys, before converting this dataset to the embedding and storing it to my ChromaDB, first of all I need to apply something called text splitter on top of it. Basically I need to convert my entire data as a chunks, because as you can see this is my complete corpus. Okay, see, this is my complete corpus. If I show you, so if I show you the data, see, this is the complete data. Okay, this is the complete data corpus, but this data set is like very huge. Okay, I can't like you can say directly convert it to vector. Okay, so if I'm converting, so what will happen? Okay, let me explain. So what is the use of this chunks? Okay, so see, so whenever you are using any LLM model, okay, whenever you are using any LLM model, so it has one input size. Okay, it has one input size, as well as it has one output size. Okay, output size. So whenever you are giving something as an input to the LLM, okay, you need to always take care about the input. Okay, so I'll tell you like where you need to check the input size and all. So in this case, let's say I'm using OpenAI LLM. Okay, OpenAI LLM. So OpenAI LLM wise, I'll be using something called GPT 3.5 Turbo. So there is a model you will get from OpenAI called GPT 3.5 Turbo, and it has actually one specific input length. So that input length actually you need to see. So if you want to check the input length, just search like OpenAI models. So this is the link, just open it up. And here you will see all the models are available inside OpenAI. So we have GPT-4, GPT 3.5, GPT based DALL-E, okay, GPT-3 legacy. So these are the model actually. And here I'm going to use this GPT 3.5 series. So I'll just click here. Now here if you see, the first model is GPT 3.5 Turbo. And this is the description about the model, okay, like what are the things they are doing and all. And this is the max token length, as you can see. So it can take an input around 4,000 97 tokens, okay, at a time. And this is the training data, okay, like up to September 2021 they have trained the data. Okay, so this is the input length. Okay, but if you check your input here, if I open my data, if you see, this input length actually will be more than this 4,000 token, because here if you see, I have loaded the entire documents. All the articles I have loaded. Okay, so there is a possibility this input size would be more than 4,000 tokens. Okay, and if I'm converting all the corpus as my vector embeddings and I'm storing to the vector database, so it will create issue. Okay, so again during storing it will create issue, and whenever you will be giving this data to your LLM model, again it will be creating issue, and you will also get some memory error and all. Okay, so it's better to split our data as chunks. Okay, now what is chunks? So let me first of all tell you, chunks is nothing but, here I have already written, chunks is a size of the maximum number of the character that a chunks can contain. Okay, and there is another concept called chunks overlap. Okay, so chunks overlap is nothing but this is the number of character that should be overlap between two adjacent chunks. Okay, so let's say, so to explain this one, let's say I will take one text here. So let's say this is my entire corpus. Okay, now first of all I need to convert it to chunks. Okay, chunks means I'll be taking some of the chunk size. Okay, let's say if I am writing chunk size is equal to, let's say, 500, so it will take let's say I'll take a new color. So it will start from here and it will go and it will count like 500 character. Okay, it will count 500 character. So let's say this is this will end here. Okay, this will end here, and this should be one chunks. Okay, this should be one chunks. Okay, so again it will start from here. Again it will count, let's say, 500 word 500 character, and we call it as a token. Okay, so let's say this is the here it will end. So this should be another chunks. Okay, so let's say this is another chunks, this is another chunks. Now again let's say it will start from here. It will start from here. Again it will count, let's say it will end here. This is another chunks. Let's say again it will start from here and it, let's say it will end here. Okay, I'm taking it randomly, just try to consider. So this is another chunks and it will start from here, it will end here. Okay, now how many chunks we have got? So 1 chunks, 2 chunks, 3, 4 and 5. Okay, so here I got 5 chunks. Okay, 5 chunks, 5 chunks of the data. See, now if you count this input length, okay, now it should be less than my 4,000 I think what is the number? It should be 4097. Okay, 4097. Okay, now my input size is less than 4097. Okay, so this is the idea of creating these chunks. Okay, instead of converting my entire corpus to the vector, first of all I need to create as a chunks. Okay, then I need to convert it to vector embedding, then I will be storing, and that embedding I will feed my LLM model. Okay, and there is another concept called chunks overlap. Okay, so what is chunks overlap? So if you set this chunks overlap, let's say I will set this chunks overlap, chunks underscore overlap, let's say I have set as 20. So what it will do, so whenever first of all I will wrap, these are the chunks. Okay, now let's create a new chunks again. So let's say whenever it will create a chunks, let's say it will start from here and chunk size is 500. So let's say it will end here. Now you have mentioned chunks overlap is equal to 20. Now what it will do, instead of starting from here, it will go back and it will count 20 character. Okay, it will count 20 character. Let's say this is my 20 character. Okay, now it will create the chunks from here. Now again it will count, and let's say your 500 character will end here. So this is my another chunks. Okay, so basically chunks overlap means like how much overlapping you are needed from your previous chunks. Okay, so that is called chunks overlap. So it helps you like to understand your context of the text. Okay, instead of using only chunk size, you can also use chunks overlap, so that it can also got to know like what was the previous context. Okay, whenever it will, let's say, see, I'm giving this chunks by chunks. Let's say this is my chunk 1, the chunk 2, and chunk 3. So okay, so instead of giving directly the chunks, if I'm also mentioning chunks overlap, so what will happen, your LLM model automatically will get to know, okay, so this is the context actually. So this sentence, okay, this sentence and this sentence, so after this sentence actually this sentence is coming. Okay, so that's why this chunk size, this chunks overlaps actually helps us. Okay, this chunks overlaps actually help us to understand the context of the entire story. Okay, so that's why we'll be using these two concepts called chunk size and chunks overlap. Okay, now I think this thing is clear. Now let me show you how to do it using code. So I'll come here. Now here, first of all, you need to import something called recursive character text splitter. Okay, so from Langchain dot text splitter, text underscore splitter, import recursive. So recursive character text splitter. Okay, so this is the class actually we'll be using to convert my entire corpus as a chunks. Okay, now I'll just call this class, and inside that you need to mention two parameter. I think I already explained. One is your chunk underscore size. Okay, chunk size. So let's define as 1000. Okay, I am considering 1000 character as my one chunk. Okay, you can give any number, so it's a hyperparameter tuning. You can set any number here, but I saw like people are starting with 1000 here. Okay, and there is another parameter you will give called chunk underscore overlap. So chunk overlap, I will give, let's say, 200. Okay, so again it's a hyperparameter tuning. Now guys, I have created this object. Now I will save this object. So I'll just create a variable called text splitter. Now guys, finally I will convert my entire corpus to my chunks. So I'll just call this object, and here you need to call split dot split underscore documents, and this is my entire documents. Okay, this is my raw documents, so I'll give it here, and I'll store in a document variable. Okay, or I can store it, I think, in a text variable. I think it should be fine. So let's make it as separate. Now let me execute. It's done. Now if I show you my text, guys, so you will be able to see it has converted to chunks, and how many chunks it has converted I will also show you. See guys, so if I just go up, so guys, see, this is my first chunks. Okay, and it is ending here. Then again it is another chunks. Okay, then it is ending here. Then again this is another chunks, and it is ending here. And from and if you see, in each chunks actually you have 1000 character. Okay, 1000 character. And here if you see the chunks overlap, so if you read this text carefully, so you will see some of the sentence are coming, okay, in this new chunks as well. Okay, because we have set this chunks overlap as 200. Okay, so see, this is my entire chunks. Now if you want to see the length, like how many chunks it has created, so just print the length. So I'll just read as my text. So it has created 233 chunks, okay, altogether. Now it's fine. Now if you want to see any chunks, specific chunks, you just give the index. Let's say I want to see the number 1 chunks. This is the number 1 chunks, and I can also print number 2. Now we have successfully converted our like corpus to chunks. Now what I will do, I will create my db object, okay, like vector db object. So just write the comment here, creating db object. So as I already told you, ChromaDB is nothing but it's a local database. So first of all, you need to create a local like DB here. Okay, local DB. So you need to specify the name. So here I already prepared this code. So here you need to first of all create one persist directory, and the name can be anything. So here in this case I'm giving as DB, that means database, and you need to specify the embedding first of all. Okay, like I think you know why we need the embedding, because first of all I need to convert my text to embeddings. Okay, that means vector. Then I will store this vector, okay, to my vector database, which is nothing but my ChromaDB. So in this case I'm using something called OpenAI embedding. I think you remember here we imported. So OpenAI embedding, so I'll just call it OpenAI embeddings. And by default, if you execute this code, so let me show you which embeddings model it is using. So it is using something called text embedding ADA model. Okay, 002. This is the model. Now you can search also here. So if you check here, so it has this model called text embedding ADA 002. Okay, so this is the model. It has also another version, text ADA 001. Okay. Now we have successfully loaded our embedding model. Now what I need to do, I need to create my vector instance. Okay, I need to like create my vector database instance. So to create it, so this is the code for it. It's a simple code only. So first of all, I have created one variable called vector db, and here I'm just calling my chroma. I think you remember we imported chroma from my Langchain. I'm just calling this chroma. So inside chroma, you have one function called from documents. Okay, from documents. Now here you just need to give the data, like you just need to give your text, like you just need to give your chunks, like which chunks actually you want to convert as a vector. So in this case, this is my chunks called text. As you can see, this is my text. I'll just copy the name, and here I'll just name it text. Okay, and it will also take the embedding model. Okay, so this is the embedding model I want to use. So in this case, you can use any embedding model. You just need to import it here. Okay, so here I'm using OpenAI based embedding model, so that's why I have initialized it here. So here I'm giving the embedding model, and here you also need to give the persist directory, like where it will save after, let's say, converting to vectors, where it will save. So it will save inside this db folder. Okay, so here I'm giving the directory. So these three parameters you just only need to give here. Okay, that's it. And if you're not giving any embedding model inside ChromaDB, it will automatically take OpenAI embedding model. Okay, I think they have already written here. If you see here embeddings, so they're automatically, I think, taking some embedding model using OpenAI API key and all. Okay, so they have already mentioned here, like it will automatically load, but it's better practice to mention. Okay, always better practice to mention here. That's it. Now if I execute it, so first of all, what you will do, I'll just remove this directory. Now see, it is converting everything to the vectors. Okay, all the text has been converted to vectors. Now I need to save it to my disk. Okay, now see, it has converted everything to the vector. Now I need to save it to the database. Okay, now this is the code for it. Just write vector db persist and vector db is equal to none. Now if I execute it, now you'll see it will create one db here, local db. Now if I refresh, see guys, db has been created. Now inside that, it has saved all the vector. Now see, it's a binary format, you can't see the vector here, so that is the issue with this local db. But whenever I will be showing you like Pinecone and Weaviate, you will able to see the vector, like how it has generated the vector. Okay, how it has generated the embedding, everything you can see in the cloud. Okay, you can like see all the list of the vector there. Okay, so that was the beauty of this cloud vector database, but again it's a local one. Okay, so that's why it's a binary representation here. So yes guys, we are successfully able to save our vector here. Okay, now let's say you want to load it. So how to load it? So this is the code for it. So here you just need to mention chroma. Okay, just call the chroma, and here you just need to mention the directory you have your data. So this is my database, DB. So here I'm giving the persist directory, which is nothing but DB in this case. And here you also need to give the embedding. Okay, so this is the embedding I'm using. Now here I'm giving my persist directory. So in this case, it's a DB. Okay, now it will automatically load this vector and everything. Okay, from this DB itself, because it's a binary representation. I already told you. Okay, and as well as I'm also giving my embedding model. Now let me load it. Now I think you remember I told you something called similarity search. Okay, now once we have loaded this vector to my vector database, now you can apply similarity search on top of it. Okay, we call it as retriever. Okay, retriever. So now let's show you the demo of the retriever. So I'll just comment it out, make retriever. Okay, so to retrieve any specific information with respect to the question you are asking, you need to set this parameter called vector as retriever. Okay, vector db. So this is my object, vector db as retriever, and this is my retriever object. Now let me execute. Now here I'll just call this retriever object, and here there is a parameter called get retrieve documents. Okay, that means I'm trying to tell my vector database whatever question I'm asking, try to give the similar kinds of you can say data. Okay, with respect to the question I'm asking. So here I'll ask one question. Let's say here I have Microsoft articles as well. I think if you see here, I think Microsoft articles is also there. So I can ask one question, just like how much how much money did Microsoft raise? Okay, so let's say this is my question. Now by default, uh, I'll store it in a docs. So by default it will return for a relevant answer. Okay, for relevant answer. If I print it, see, it will return you for similarity answer. Okay, for most similar answer. Okay, like whatever vector are closed, I think I was explaining in the theory. So it is the most relevant and most similar answer. Okay, for most similar answer. So if I show you the length, so you can also set this parameter like how many relevant information you want. See, it is returning me 4. So let's say you only want, let's say, 2 relevant answer. Okay, so in this case you can set this parameter vector db as retrieve, search keyword as k2. Okay, k means like how many answer you want. Okay, so let's say I have given 2. Now if I execute it, okay, done. Now if you want to see like search type, so it's a similarity matrix. I think they're using similarity equation, they're using cosine similarity to calculate this answer. Okay, like the question you are asking, basically it will match with the vector, like what are the closest vector. Okay, it will come, so it will return you. So they're considering this similarity cosine similarity matrix, I think they are. Okay, so cosine similarity equation, and this parameter will give you like number of return actually it will provide. So it will only provide 2 answer. Okay, 2 answer. Now if I again execute this code, now see guys, now length is 2. Okay, it is only returning 2 answer. Okay, so using this parameter you can set like how many like answer or how many similar answer you want. Okay, from your database. Okay, now see guys, it has returned 2 or let's say 4 similar answer, but I want a specific output. Let's say the question I asked. Okay, let's say if I print my document, so it's a different kinds of answer actually it will return. Okay, but it's not understandable actually. It's like it is giving like lots of answer and all. Okay, it's giving lots of text, but I want like a relevant answer. Like I just asked like how much money did Microsoft raise, so it should give me like that is the money Microsoft raised. Okay, so it should give me that kinds of answer, but it is returning this kinds of document. Okay, these kinds of chunks. So to get a specific output, okay, from your data, you can take a help from the LLM. So what you can do, let me show you the diagram. So let's say this is my vector db. Okay, now we have stored our vector embedding here. Vector embedding we have stored here. Okay, now you are giving uh, any kinds of query. Let's say this is your query. So here in this case, let's say you asked like how much money Microsoft raise, right? So this is your question. So it is returning, let's say 4 or let's say 2 output documents. Okay, but this 4 or 2 output documents is not readable. Okay, I am not getting my specific answer. So what I can do, I can integrate LLM model. So let's say I will initialize my large language model here, which is nothing but GPT 3.5 turbo in this case. Okay, turbo. So I'll give this answer to my LLM model. Okay, I'll give this answer to my LLM model, and LLM model will analyze this answer. It will also analyze this query. Okay, it will also analyze this query. With respect to that, it will give me the authentic output. Okay, the correct output, correct, meaningful output. Okay, that is the power of LLM. I think you know why it is powerful and all. Okay, because it has trained with huge amount of unstructured data, so it can perform all kinds of tasks. Okay, that's why uh, we will be using LLM, okay, to retrieve our specific answer with respect to the specific question I'm asking. Okay, so this is the idea. So now to do it, actually, first of all, I need to make one chain. Okay, so let me just comment it out. I think you know what is chain in Langchain. Okay, so I'm not going to explain because I think you already learned this chain in Langchain. Okay, why we use chain and all. So first of all, I need to import something called retrieval QA chain. Okay, so I'll just write from Langchain dot chains import retrieval. So whenever you are using vector database, okay, it is returning retrieval output, right? Like related output. So you need to use this retrieval QA. That means retrieval question answering chain. Okay, so it will help you to ask the question, okay, to the data actually you have stored in your DB. Okay, so that's why this chain is required. Retrieval question answering. So I'll import this chain. Now here, first of all, you need to make one chain. So I have already made one chain here. So this is the chain. So I'm just calling retrieval QA chain, and there is a function called from chain type. So here you need to specify the LLM model. So here in this case, I'm using OpenAI LLM model. Okay. So let me show you how it will give you the model. So if you just run it in a new cell, now if you print this LLM, so this is nothing but your GPT 3.5 turbo. Yeah, so it's not giving the name, but if you see the documentation by default, whenever you call OpenAI, so it will give you something called GPT 3.5 turbo. Okay, this model actually, if I GPT 3.5, so this model actually it will return. Okay, so I'll be using this LLM, and here I'm giving this LLM model, and chain type is stuff. Okay, I think you already know what is chain type and all. And retriever, so you need to give the retriever object here. Okay, this is the retriever object. So basically, whatever question you are asking, okay, whatever question you are asking, it will return you from this retriever, right? Because you have given this retriever here. Okay, so that's why you need to give this retriever object here, and you also need to give the return source documents. Okay, return source documents means it will return the source also. Like, see, we have lots of data here. If I show you, we have lots of article here. Okay, now which article it is referring to give the answer. Okay, it will also give you as a reference that article. Okay, so this is the idea of this. Now if I execute, now let's ask one question and print this response. Okay, so here I'm calling my QA chain, and this is the query. Same query I'm asking, how much did Microsoft raise the money. Okay, so this is the query I'm giving my inside my chain, and this is the response of the LLM. Now if I print this, see guys, this is the query. Now it's telling around $10 billion. Okay, raised like this Microsoft, and this is the source document. Okay, but it's not readable. So what you can do actually, you can write one function here, process LLM output or process LLM response. So this is the function you can write. So whatever response it will give, it will process only, like it will give it the result, source, and the answer. Okay, now if I execute, now if I call this function here, now I'll just remove this response here. Okay, now I think it should give me the yeah. So now you can see this is the clear output. Now around $10 billion, and these are the source. Actually, it has referred this to file as a source. Now see guys, we are able to successfully store our vector to the vector database, and we are also able to make the query on top of that. And we also saw that like how we can found the similar kinds of you can say output, okay, using this retrieve, okay, using this retrieve option. Okay, so you can ask any different question also. So let's say I will ask another question here. So what is the news about Pando? So there is again another Pando articles you will see inside the data. Now again, I'm giving inside my chain and it is giving the response and I'm just processing the response. Now see, Pando is a startup that has raised $30 billion in a Series B round and bringing its total raised. Okay, so this is the complete answer and this is the source it is giving. Okay, I think I don't need to print this. Yeah, so this is the source. So yes guys, that's how actually you can do it. And one thing I also want to show you, like how to, let's say you want to delete this database, so how to do it. So deleting DB, so it's like very easy. First of all, you can make a zip file, okay, of your existing DB, so that later on if you want to retrieve it, you can retrieve it. Okay, so first of all I'm making it a zip file, then I'll be deleting it. So first of all I'll make a zip file. Now see guys, if I refresh, so first of all it will make a zip file of this DB. Okay, now I'll be deleting. So this is the deleting code, so it will clean up everything. Now if I refresh, now see database has been deleted. Okay, now let's say you want to get your previous DB. Okay, like you had, let's say some specific or let's say important vector there, you want to get back. So what you can do, you can unzip that zip file. Okay, so this is the zip file, you can unzip. Now again your database will come. Now what you need to do, you need to restart the runtime. Okay, so just click here and there is option called restart the runtime. If you restart the runtime, again you can able to use your DB same wise. Okay, like we already imported our DB right here. So here, that's how we can load your DB again. Okay, so this is the functionality actually ChromaDB provides. Okay, if you see the documentation, they have written everything. Even they have also given the starter notebook and all. Okay,
so guys, I think as of now you got the entire idea about the ChromaDB, like how we can use ChromaDB vector database and how we can connect the large language model and how we can perform this let's say vector search operation, right? So one thing I just wanted to show you, see if you click on the integration, see this ChromaDB is having like different integration. That means you can use ChromaDB with OpenAI, Google Gemini, Cohere, Hugging Face, okay, Instructor, Hugging Face embedding server, Gemini AI, RoboFlow, okay, Llama embeddings, everything you can use. Okay, everything you can use with this ChromaDB. Now we can see some framework integration, like it can also support LangChain, LlamaIndex, then BrainTrust, LLM tree, okay, then Streamlit, HighStack, OpenLit. So these are the framework also you can connect. Okay, that means it has actually all the integration. If you're using different framework, different let's say large language model, different platform, everything it can support. Okay, so as of now we saw like how we can use with the help of LangChain. Going forward we'll be also learning how we can use with the help of LlamaIndex and so on, right? So yes guys, this is all about from this video. In the next video we'll be learning another amazing vector database called Pinecone, and Pinecone is a cloud-based vector database. That means we can store our embeddings in the cloud platform. As I already told you, Pinecone is a cloud-based vector DB. That means you can store your embeddings to the cloud. So if you want to use Pinecone, so search for actually Pinecone in the Google. So Pinecone. So you will get the first website. Just try to open it up and make sure you create one account. Okay, you just need to create one account inside this website. So for this, you just do the sign up operation. So with the help of your Google account, you can create one account. So once you have the account, just try to do the login. So I already have the account, so I'll just try to do the login here. So once you have logged in guys, you will get this kinds of dashboard. So guys, now let's try to see how we can use this Pinecone vector database to store our embeddings. So guys, what I've done, I already recorded one video previously on this Pinecone, the detailed video, how to use this Pinecone and all. So I'll add this video here. So this video will give you the entire idea how we can use this Pinecone with the LangChain and all. So guys, as you can see, recently they have updated their dashboard, but previously it was actually different kinds of dashboard. But see, functionality wise, it is same. You have to use as it is, but somehow actually they have updated some kinds of actually dashboard. You can see previously this index was like out. That means there was a option called index, directly create index option was there, but they have actually created this index now inside databases. Okay, see inside databases now there is an index option. So guys, this Pinecone is not a free vector database. For this actually you have to take the subscription, but if you are creating, let's say, new account for the first time, here you will get actually a free actually some storage. That means 2 GB storage you will get. That means you can only create one index there. That means one cluster you can create. So if I click on the create index, you will see I can only create one index. And whenever you are creating free index, make sure you are selecting Google Cloud. Okay, not any other cloud. Otherwise, actually it will ask for the charge. See, I already occupied my, let's say, free plan. Now if I click here, see, it will ask for the upgrade. That means I have to upgrade with their, let's say, subscription. I already utilized the free plan, but for you actually will see the free plan option is there because you have created the new account. But for me, I already use this account. Okay, that's why it is showing I don't have any free plan right now. Fine. So make sure guys, you just try to create a new account and try to use this Pinecone. And to create the API key, guys, just click on the API key and here you can create the API key. Okay, and this API key will help you to connect with your this Pinecone server. Okay, from your Python code. Now let's try to see how we can use this Pinecone vector database without LangChain. And guys, one thing, whenever you're installing Pinecone client, make sure you're installing 2.2.4. Okay, this particular version, because whenever I was using this Pinecone, that time actually this version was the stable version. And try to use this version, guys, because this version will help you a lot, because it is having like very easy syntax to store the embeddings to the Pinecone server. So make sure you're installing this 2.2.4 version. So let's try to see how we can use this Pinecone right now.
First of all, you need to install some required packages. So just let me write down the comments here. So I'll be installing, these are the packages. So I'll be installing something called LangChain, then Pinecone client. Okay, so if you want to use this Pinecone vector DB, so you need to install this package called Pinecone client, and this is the Python package, and it will help you to connect with this Pinecone. Okay, then I also need PyPDF library, because here I'm going to load PDF data. So previously I showed like how to load TXT data. Now I will show you like how to load PDF data. So I'll show you like all kinds of data, like how to load and all. Okay, so that's why I need to install. These are the packages. So let me install. So guys, as you can see, my installation is done. Now I'll take some new cell, and here I also need OpenAI and tick token. Okay, I think you already saw from my previous demo. So OpenAI is also needed because I'm going to use OpenAI embedding, and as well as this tick token because I'm going to use OpenAI embedding. So tick token is the dependency there. Now installation is done. Now let's import some of the libraries here. So here I'm going to import, these are the libraries, and I think you are already familiar with these are the libraries, why I'm loading and all. I also need something called operating system. So I need this PyPDF reader loader, because here I'm going to read like PDF data. So for this actually I need to load this one from documents loader, but previously I was loading like text loader. Okay, so this is the difference. Then recursive character text splitter means like you want to make your data as a chunks, because I told you why this chunks is required and all. So that's why this is needed. And OpenAI embedding I will be using, and OpenAI LLM model, that means GPT 3.5 turbo. So for this actually I'm using this OpenAI LLM. Then from LangChain I'm also going and here from LangChain I'm also importing like vector store, which is nothing but my Pinecone, but previously I was loading my ChromaDB. And retrieval QA means like you can also make some question answer, okay, on top of your data you have stored in the vector database. I think I was discussing, okay, with the help of this chain. Then you can also import something called prompt template. Basically you can give your custom prompt here. So this is also possible. Okay, I'll show you one demo here. So let's import these at the library. So first of all, here what I will do, I will create one folder. So let me first of all give one title like load data. So first of all, I'm going to create one folder here called PDFs. So inside that, I will download some of the PDFs I have in my Google Drive. So this is the code to download anything from the Google Drive. So here, if you see in Google Drive, you will see this ID, okay, of any kinds of file. Otherwise, you can download it and manually upload it inside. Okay, it is also fine, but I'm just downloading. So I have one yellow V7 paper in my Google Drive, and also I downloaded one resume. Okay, like from Google itself, I've downloaded one resume. So the name of the resume is like Rachel Gree CV. Okay, so this is the resume I've downloaded. So these two files I'm going to download inside my PDF folder. And with the help of this gdown package, you can download anything from the Google Drive. Now if I refresh and if I show you my PDF, so see, these are my data are available inside that. Okay, now what I will do, first of all, I need to extract the text from the PDF. So for this, let me give one title here. So how to extract the text from the PDF. So this is the code. You need to take the help from PyPDF directory loader, and here you just need to provide the path of the PDF file you have. So this is my path like PDF. So here I'm giving the path, and once you have given the path, you just need to call this load function and it will automatically load the data. So let me show you. So it has loaded my data. Now if I print my data, you will be able to see my data. See guys, all of the data has been extracted. Okay. Now what I need to do, I need to convert it to chunks, because I can't directly convert it to my vector, because input size might be vary, because I told you whenever you are using a large language model, so it has one input size. Okay, so you always need to take care of the input size. So that's why we need to create as a chunks. So to create the chunks, so this is the code, I think you remember. So I'll be just calling this recursive character text splitter, and here you need to give chunk size and chunks overlap. Okay, I think I have already discussed what is chunk size and chunk overlap. Then simply I'll just execute it, then I will apply on top of my data. Okay, so this is my entire data, and here I'm passing this in my text splitter object. Okay, now it will give me the text chunks. Now let me execute and show you. So guys, this is my text chunks. Okay, see, this is another chunks, this is another chunks. So let me see like how many chunks I got here. So length text chunks. So I got around 168 chunks here. Okay, now if you want to see any specific chunks, so you can also print. Let's say I want to see number 1. You can also print for other. This is number 2. Okay, now here if you read it carefully, you will be able to see like also some chunks overlap is also there, like some text is coming from the previous chunks also. Okay, now guys, you can also print like third one as well. Now guys, first of all I need to download the embedding. So download the embedding, first of all you need to set up the environment. You need to first of all what you need to do, you need to set up your OpenAI API key. Okay, so I think you remember I can use my previous notebook. So in my previous notebook I already created this API key and I already set up my environment. I'll just copy this code and here I will paste it at. Okay, now I'll set my OpenAI API key. So let me set it. Yeah, now first of all I need to download the embeddings. So this is the code for it. So it will give you the embeddings, like OpenAI embeddings. Now first of all let me test one thing here. So what I can do, I'll just call my embedding. Like I just want to show you like what is the length of the vector it will generate. Okay, so I'll just call embedding.embed query, and here if you pass any word, let's say I will give hello. Okay, now if I execute, you will able to see the vector. Okay, see, this is the representation of the hello. Okay, and this is the vector. Okay, this is the vector representation, numerical representation. So I'll store it in a variable called result. Okay, now if I show you the length of this result, so let me see the vector length. Yeah, so by default actually if you are using OpenAI embedding, so the each vector length would be 1536. Let's say if I give any word here, let's say I'll give something called good. Okay, let's say good. If I give good, so you will see the length would be same. Okay, now if I give, let's say anything like I can give hello, or let's say how are you, how are you. So again the length would be same. See, length would be same. So basically what is happening, I think I was discussing this thing in my theoretical lecture. So whenever it is like trying to generate these kinds of vectors, okay, so it was following this approach. Basically it was creating some features. Okay, so with the help of the features actually it was generating these kinds of vector. So basically what is happening, so the sentence you have given, so this sentence is representing in this dimension actually 1536. Okay, this is the dimension of the sentence. Okay, and it is representing in that. Here I was referring this word by word, but you can refer as a sentence by sentence. So basically this king is appearing in this dimension actually 1 2 3 4 5 6. Okay, 6 feature we have created. So this was the 6th dimension. Okay, 6th dimension, this king was representing there. Okay, but whenever I'm using OpenAI, so I have written like how are you there. Okay, how are you is representing with the help of 1590 sorry 1536 vector. Okay, this is the dimension. Okay, if I plot it, okay, so this should be the dimension and this is the representation of the how are you. Okay, I think you are getting like how it is generating this vector and all. Okay, so if you give any sentence here, so this should be the length. So now I need to store these are the vectors. Okay, like I will apply this vectors embedding on top of my data. I have created the chunks, then I will store it on in my Pinecone vector database. So for this, first of all, I need to initialize the Pinecone. So let me initialize it. So for this, first of all, what you need to do, you need to collect some Pinecone credential. So you need to collect like Pinecone API key and Pinecone environment. Okay, so how to collect it? So just go to Pinecone, and this is my dashboard, and here I already told you how to collect this API key. Just create a API key and try to just copy, and here just replace your value. Okay, no need to use my value because I'll be removing my keys, so you need to use your value. Okay, so just try to replace this value. Okay, then you need to also collect something called Pinecone API environment. Okay, so how to collect it? So here if I go to now just click on index, so here you just need to create one index here. So first of all it would be empty, and here you just only can create one index because it's a free one I am using. Okay, now I'll just click on create index and need to give the name. So here I'm using, let's say this is my test, or you can give any name. I'll give test index, and here you just need to specify the dimension of the vector. Okay, now here I already showed you, so this is the dimension of my each vector. Okay, so this is the dimension. I'll copy this value and here I'll just write it, and you can also select the metrics, like what kinds of metric you want to use to retrieve your similar kinds of vector. Okay, so by default it is cosine. You can also use Euclidean and dot product, but cosine is a little bit fast. Okay, because if it calculating cosine distance, okay, so it will be like a little bit fast, okay, to calculate, because I was already discussing, right? If I show you that graph, so see, if I want to calculate cosine similarity within this two vector, so it will just create one angle here and it will give me the cosine similarity score. But if I'm using Euclidean distance, so it will just calculate with respect to all the data points I have here. Okay, so that's why cosine is first in this case. Okay, so I'll be using cosine metric. Now here, this is the default pod you need to select, and this is the free plan I already told you. Now I'll just create the index. Now see guys, it is initializing, so you need to wait for some times. Once it is done, so it will give you this green status. Okay, now see guys, it has created. Now here you will see the environment name. Okay, and this is the GCP provider. So basically this cluster has been created in the GCP cloud, and this is the region, and this is the environment name. So this parameter you can set if you are taking their paid subscription, but by default if you are using free one, so they will assign these kinds of provider and region. Okay, now I'll copy this environment name, and here I'll just need to replace. Okay, so for me I have already replaced, which is nothing but GCP starter. Okay, now let me just quickly set this environment variables, okay, inside my environment. Now here I will initialize my Pinecone. So if you visit Pinecone documentation, so they have given this code, like that's how you need to initialize Pinecone. So here you just need to provide this API key. So here is my API key. It will read from my environment, and here is my Pinecone API environment. So this is the environment. So it will automatically read it and it will initialize that. Okay. And here you also need to provide the index name. So this is my index name we have created called test. But if you are creating any other name, you can give the same name here. Now let me just quickly initialize this Pinecone. Yeah, so it has initialized. Now what I need to do, I need to create embeddings from my chunks. So let me first of all comment. So to create the embeddings from the chunks, so this is the particular code you need to execute. So first of all, here, whatever embedding I'll be generating, okay, so I'll store it in my Pinecone. That's why I'm just writing Pinecone from text. Okay, and here I've just written one list comprehension. Okay, I think you know list comprehension in Python. Okay, so basically the chunks, text chunks I have, so I'm just reading one by one. Then I'm just reading the page content. Okay, then this is my embedding object, I think you remember. So this is my embedding object, and I'm also passing my embedding, okay, embedding objects, and also I'm giving my index name. Okay, that means this is the index name. So this Pinecone client will automatically take it, and it will automatically convert your chunks to embedding with the help of this embedding objects, and it will store inside this index name. That means this index. Okay, inside this index it will store all of my vector. Okay, and it will give you one object called docSars. Okay, now let me just quickly execute and show you what will happen. See guys, it is taking all of my chunks one by one, and it has converted to vectors, and it has stored inside the Pinecone cluster. Now if I go to my Pinecone cluster, and here if I refresh this page, so guys, as you can see, I refreshed my page, and now I am able to see all of the vector here. If you see, if you just click on browsers, so here is the vector. Okay, and first of all, it will show you the, like top 50 vector here. If you see, this is the representation. So this is the text, and on top of that, actually this is my vector. Okay, I'm getting. So you can also copy the vector, and you can also see. Okay, and the length of the vector is this one. Actually, I think you remember, 1536. Okay, this is the length, and this is the beauty of this cloud vector DB. You can see your vector here, like how this vector has been created and what is the text with respect to that, and you can also see the scores. Okay, like what is the scores with respect to these vectors, like this is the distance actually. Okay, that's how it create the index. Okay, I think I was also talking about like index in vector database, right? Indexes in vector database. This is the score. Okay, using this score, actually it try to figure out the similar kinds of vector whenever you search any query, right? So this is the beauty of this vector, and I love this Pinecone one because it looks very easy, and it's like very beautiful interface it provides. Okay, and you can also see the second page, and you can see all kinds of vector here. Even you can also change the parameter. Let's say I want to see top 100 vector here. So if I just search the query, so it will give me all the 100. Okay, 100 vector here. Okay, so yes guys, and you can also see the metrics, like how many times you are raising the request and all. So it will give you all kinds of log here, like if any request is failed, so it will give the error logs and all, everything it will give you. Okay, so yes, so this is the simple interface of my this Pinecone, and vector counts is 168, because if I show you my chunks, okay, my chunk size was 168. So that's why you are able to see this vector count is 168, because I had 168 chunks. So with respect to that, this vector has been created. Okay, so yes guys, this is all about my Pinecone one. Now we are able to successfully store our data here, and this is the cosine, and this is the dimension, and all kinds of host and provider you can see here. Now let me show you like how to query out on top of your vector and all. So for this, what you can do, you can use something called similarity search. But before that, let's say if you have already one cluster here. Okay, so what you can do, you can load this cluster directly instead of storing that vector again and again. So this is the code for it. So let's say I have already one cluster. So you just need to give the index name, which is nothing but, let's say, test. And here you also need to give the embedding. Like here I'm using OpenAI embedding. So here I'm giving the embedding objects. Now if you execute, it will automatically load this index. Okay, it will automatically load. These are the vector here. Now see, it has loaded this vector. Now on top of that, you can perform similarity score operation. Now here, let's say I will ask one query. Let's say I have one YOLO V7 paper here. I think you saw that. So here I'm raising one query like YOLO V7 outperform which model. Okay, like we have lots of YOLO model, right? So from them, actually YOLO V7 performs actually which model. So this is the query I'm asking. So now this query, I will give it to my docSars. This docSars, this is the object. Okay, basically it will have all the like you can say vector objects and all. Okay, so here I'm going so here actually I can directly ask the query. So it has one function called similarity search. Okay, so inside that you just need to pass the query, and you need to set the k. Okay, I think you know what is k. So k means like how many output you want to get, okay, from your search results. Okay, so it will give me 3 results. Okay, now if I execute and show you, query is not defined because I haven't executed. Now let me show you. See, so it will give me a top similar 3 output. See, this is the 3 output it has given, but again it's not readable. So what you can do, you can take the help from LLM. So LLM, if you give this query and this output to the LLM will try to understand this query and the output, and it will give you the best answer, okay, from them. So here let's ask this query to my LLM. So I'll first of all initialize my LLM. And here I'll be using a retrieval question answer from Langchain. I think you remember I was also using. and chain type is stuff, and here I'm just giving this retriever objects as my doc source, okay, and as retriever, okay. You need to give it like that, then it will consider you are you want to ask any kinds of question, okay, and you want to get the answer. Now let me initialize this question answer object. Now you can ask the query here. So I'll ask the same query. So this is my query, and I will ask it to my LLM model. So I'll just initialize QA.run, and if I give the query, so it will give me the answer. See guys, YOLO V7 outperforms YOLO V5, L6, YOLO X, YOLO EX. Okay, so these are the model actually. It outperforms. Okay, see, it is giving the correct answer. Now I'm not getting these kinds of answer. Okay, I'm getting my relevant answer. Now I have one resume. I think you know. Okay, I have one resume also. Richard Gray CV. So let's ask some query from this resume also. So here is one question I prepared called Richard's Green experience. Okay, like what is her experience? Okay, so see, it will automatically give you that experience as well. This is the power of LLM. See, it's giving Richard Green has a PhD in English from the University of. It is giving like some more information about Richard Green, but it's pretty good, right? Yeah. So you can ask any kinds of questions. So you can also create one while loop here. So let me show you how to create while loop. So this is the while loop I have created, and here I'm taking the user prompt. So here you need to import one library called sys. Basically, whenever you are you want to exit, so you can exit it also. So this is like input I'm taking from the user, and if user is giving like exit, so it will exit. Okay, this code would be exit, and if it is not, then it will take the query and it will return you the answer. Okay, now let me show you. So if I ask like what is YOLO V7, now if I press enter, so it will give me the answer. See, YOLO V7 is a real-time object detection which surpassed all known object detection in bound speed and accuracy. Okay, it's giving the correct answer. Now let's ask any query. Tell me about Rachel Green. Yeah, I think Rachel spelling is not correct. I think it should be. Now let me ask. See, it's giving the correct answer. Okay. Now if I press, let's say, exit, now it should exit the, yeah.
Okay guys, I think you saw the entire like demo, how we can use the Pinecone, and you got the clear cut idea. Now in the next video, we'll be learning another amazing vector database called Weaviate. Weaviate is also a like you can say cloud-based vector database. There also you can create a cluster and you can store your embeddings. So if you search Weaviate in Google, you will get this documentation. So here they have already mentioned like how to connect this Weaviate with the Langchain and all, everything they have given, all the integration and all, how to install, okay, how to configure, everything they have given. So guys, what I've done, I prepared one notebook. This notebook will give you the entire understanding like how we can use this Weaviate vector database. Now this is the official website of the Weaviate, Weaviate.io. So here you need to create one account first of all. Make sure you have created the account, and after creating the account, actually you will get free credits. With the free credits, you can only create one cluster. The same way you did for the Pinecone as well, right? And again, it's a paid one, guys. You have to pay if you want to use their, let's say, advanced, let's say, functionality. You have to pay for that. So here we'll be only exploring the, let's say, free one, the free tier one, because free tier one is enough for learning. Fine. Later on, if you need it, you can also upgrade your subscription. So if you want to create the account, just click on Try Now button. So you will see they will ask for the email and password. With that, actually, you can create your account and you can log in with this Weaviate. So guys, now let's try to see the practical how we can use this Weaviate vector database.
So here, first of all, you need to install some of the libraries. So these are the libraries are common. So here, so guys, here now I'm using something called Weaviate. So this is the like Python package like Weaviate client. So you need to install this package to connect with your Weaviate. Okay, Weaviate cloud database. Now let me just quickly set up them. Now guys, what to do, you need to collect some of the credentials. So these are the credentials are required. So first of all, I need my OpenAI API key. then I need my Weaviate API key and Weaviate cluster. Okay, cluster URL. So this three thing actually I need. So I think we already created my OpenAI API key. Just try to copy from my previous notebook. So here is my API key. So I'll just copy. And here I will just try to paste it. Okay. Now let's see like how we can collect this Weaviate API key. So for this, just visit your Weaviate dashboard, and here just try to create one cluster. Just click on create cluster. Okay, you need to give the cluster name. So let's give any name. So I'll give test. Okay, so you can give any name. So everything will remain same because this is a free one, and it will expire in 21 days because this is the free version, free tier I'm using. Okay, but if you want to use for your production grade applications, at that time you can take the subscription. Okay, now just try to create the cluster. So it will take some time. Once it is ready, so it will give you the status message. And guys, if you see, Weaviate also support these kinds of client like Python client, Java client, CLI, TypeScript, then Go. So it has actually multiple client support. So like those are working in Java and all, so you can also use it. Now guys, see, my Weaviate cluster is ready. Now if I click on detail, now here it should give me that detail of my cluster. Now here, first of all, I need to copy this cluster URL. Okay, just copy this cluster URL here. From here you can also copy. Now let's go back to my Weaviate, and here you need to paste it. Oh sorry, this is my API, so I need to paste it here. This is my cluster URL. Okay, now I also need to copy the API. So here is the API option. Just click here, and this is the API key. Just try to copy and don't share. I'll delete it after this recording, so that's why I'm sharing. And I'll just paste it here. Okay, now I got my 3 credentials. Now let me execute them. Okay, so first of all, I need to read my data. So let me read the data. So here, first of all, I will create one directory called mkdirs data. Okay, now data folder has been created. Now inside that I will upload one. PDF file I have here. So this is the YOLO paper, actually YOLO related content. So you can download any kinds of PDF and you can upload here. No issue with that. You can either use text data, okay, doc data. It's up to you. So guys, as you can see, my PDF has been uploaded here. Now what I will do, I'll just try to load this PDF, okay, and I'll just extract that text from it. So let me show you like how this PDF will look like. So guys, see, this is the YOLO like presentation. Okay, so I have downloaded as PDF. I'll just execute this particular code. So here I'm giving the data directory and I'm telling just load the PDF file. Okay, then I'm loading the data. Now let me load. So it's giving one error. It's telling unstructured package not found. Please install it with pip install unstructured. Okay, so what is happening actually? So if you see here, I have downloaded this Google, like you can say slide. Okay, Google slide as PDF. That's why it is considering as unstructured PDF. Okay, so that's why we need to install one package called unstructured PDF. So let me install it. So this is the command to install. But if you are having like PDF, like very simple PDF, so you don't need to install it. Okay, so this is for like unstructured PDF. So if you have any complex PDF, so you need to install this package. So previously I was using like paper and all. Okay, that's why it was simple PDF, but now I'm using like Google slide PDF. That's why it's giving this error. And it's pretty good. Like it will tell you like what are the packages you need to install and all. So it will give you the message as well. So guys, it's done. Now it's telling just restart the runtime. So let's restart our runtime. Okay, now let me execute this code. Now it is extracting all the text from this PDF. You can also upload multiple PDF here. It's up to you, but I have already added one PDF. I just want to show you the quick demo. Done. Now let me show you the data. So guys, this is the entire data I got from my PDF. Okay. Now I need to apply something called text splitting. I think you remember. I need to convert it to chunks. So let's convert it. So recursive character text splitter. Okay. I'm importing from Langchain, and this is the chunk size and chunks overlap. You can give any number here. So let me just do it quickly. Now I got my chunks. Okay, see, this is my chunks, and also let me see the length. See, all the things are common only. We are just changing the database client. Okay, like I'm using ChromaDB, Pinecone, and Weaviate. So just client is changing, but steps are same. I think you are getting. Now I need to convert to embeddings. So let me just comment it out. So here I'm going to use OpenAI embedding. OpenAI embedding, and here you need to pass the OpenAI API key. If you're not passing, it's fine. You need to add inside the environment variable. So previously we added, if you see here, environment variable, but here I'm not adding environment variable. If you're not adding inside environment variable, you can directly pass them. Okay, that will also work. Okay, it's giving error. OpenAI is not defined because we have restarted the runtime. So I need to execute this cell again. Now I think it should work. Now here I'll be initializing my Weaviate vector database. So if you visit Weaviate documentation, there is the documentation, and here they have given the installation guideline, then configuration, then what is the schema, libraries, everything they have explained. Okay, so you can visit the documentation and you can get all the information. But here I already gone through the documentation and I prepared this notebook. So this is the code actually you need to write to initialize your Weaviate actually. That's why actually I like Pinecone one, because Pinecone looks easy. To me, because what I feel like Pinecone is like more easy, and it's like more easy to understand and like more clear. But if you're using Weaviate, so you need to write some extra code it. Okay, but it's completely fine. Okay, no issue. You can use it. I will share my notebook. You can use this notebook as it is. So here I'm just first of all importing Weaviate from Langchain. You can also import directly. It is also fine. Now here you just so first of all you just need to connect with your Weaviate cluster. Okay, this cluster we have created here. I think you remember this is the cluster. So to connect with the cluster, you need to give the API key, Weaviate API key, and I think you know we already collected the Weaviate API key here, and I stored in the variable. Okay, then I also need collected the cluster URL. Okay, both I have collected. Now cluster URL you also need to give. Then you need to initialize the client, and inside that you need to give the cluster URL and as well as the OpenAI API key also, because using the OpenAI API key, it will use the OpenAI embedding. Okay, whenever it will convert your data to vector embedding, so it will use that OpenAI embedding. Okay, so that's why you need to give the OpenAI API key here. Now I also need to give something called authentication configuration. So this is the authentication configuration, which is nothing but my API key, Weaviate API key, and this is the startup period. These are some default parameter you need to give, and let's execute. Okay, now if you want to check it whether this client is ready or not, so this is the code for it. So is ready. So now it is true. That means my client is ready. Now it is connected with my Weaviate client. Now Weaviate is telling you need to prepare something called schema. Okay, here they have given one client schema. So if you visit this client libraries, okay, so here if you see example client schema, so you also need to define some schema here. Schema is nothing but it just it kinds of configuration it will take, okay, as an input. Like you can change the configuration with the help of code. So that's why these are the things they are giving. But if you're not able to get it, okay, it's completely fine. So you just need to give this schema and it will come on for every experiment you'll be doing. So this is the complete schema, guys. Okay, so client schema detail. First of all, if it has any schema, it will delete, then it will add this schema. So here you can give any name. Okay, so I have given chatbot here. Then here you can give any description. Then what are the vector actually model you are using, you can give the name here. So in OpenAI actually you have ADA model. Okay, so here I'm using ADA model, I think you remember. if I print my embedding, so here I was using something called ADA model. Okay, as you can see here, I was using something called text ADA embedding ADA model. That's why you can also give the name, and these are some description you can give, and after that you can create the schema and you can create your client. Okay, now this is the code, so you can execute. And this thing is not required in Pinecone, so Pinecone can handle these are the thing automatically, but in Weaviate you need to provide. That's why I personally like Pinecone. Okay, now once it is done, you need to initialize the vector store. Okay, so now this code will initialize the vector. So what it will do, basically it will take your documents. Okay, I think you remember we have created the documents. Okay, we have created a cluster, and from this cluster with the help of this embedding, we are just trying to generating the vector and storing inside our Weaviate. Okay, now let me execute and show you. Now see guys, now if I go to my Weaviate and refresh, now it hasn't updated yet. So after some times you will see it will update, like how many embeddings had generated. Okay, then how many times you have you can say did the request, everything it will show you here. Okay, so all the information actually it will give you, and these are the, and guys, these are the embedding model are available by default with this Weaviate, so you can use any of them, it's completely fine. But we are using this ADA model, OpenAI generative model. Okay, so yeah. So guys, usually it takes some time, around 5 to 6 minutes. After that you will able to see all the update here. So in between what I can do, I can show you the other step. Now we have successfully stored our embeddings. Now let me just do the similarity measurement, that means similarity charts. So here, first of all, I will ask one query called what is YOLO, because this is the YOLO related content, and here I'm initializing this similarity charts. Okay, because the vector store is this is my object, and on top of that I'm just writing similarity charts. Here I'm giving the query, and top k, that means how many output you want to get. So here I'm given 20, you can give any number. Now it will return like 20 results. Okay, 20 similar kinds of results. See, okay, but I can't actually take the answer. So what I can give one chain with the help of Langchain. So here there is another parameter called question answering. Okay, load QA chain. You can also use this chain. Otherwise, you can also use retrieve QA chain. Okay, that is also fine. Now here I'm going to use OpenAI LLM. Now I'll define my chain, and here I need to pass my OpenAI API key, and this is the chain type. And temperature means like if temperature is 0, so your model would be like more you can say stick to the answer, like it won't be giving any randomness. And if you're changing the temperature to close to 1, so it will give some random output as well. Okay, so this parameter you can change. I think if you have learned like LLM, so I think you know this parameter and all. Okay, so these are like basic thing, okay, in LLM. Now let me define my chain. Now here I will ask this query. So chain.run input documents. So this is my documents. This is my entire documents I'm giving. Okay, the documents I have, and see, this is the documents. That means I got all the answer, right? 20 answer, and from this 20 answer I want my query. That means the query I'm asking, which is nothing but what is YOLO. So now with the help of my LLM, I will get my authentic answer. See, YOLO is an algorithm for object detection that is unified, real-time, and has higher accuracy. It is presented by Shivang Singh, and this is the date of the publication. Okay, so yes, I'm getting my output and all. So now you can ask any kinds of question about YOLO and all. Okay, I think you got it. Like I already showed you multiple times. You can either create one while loop, and you can ask many question here.
All right, guys, I think everything is clear now. How we can use this Weaviate vector database. So we have learned different vector database, guys, so far. Now we'll be using all of them to implement different like Gen AI application. If you don't know about Langchain is a generative AI framework. With the help of that, we can implement any kinds of generative AI based application with the help of large language model. So I think you already used something called PyTorch and TensorFlow whenever you used to learn deep learning, right? So inside deep learning, we used to implement computer vision project, NLP project. So there we used to use these kinds of framework like PyTorch and TensorFlow. So both are actually deep learning based frameworks. So with the help of that, you can create a neural network, right? That means all the functionality this framework provides to implement any kinds of neural network to, let's say, work with your data, to load your image, everything you can perform there. So similar wise, if you want to work in the field of generative AI, so inside generative AI, if you want to work with the large language model and all, So you have to use this LangChain framework because LangChain is having all kinds of integration, all kinds of functionality. Okay, so only you just need to learn how we can use this LangChain properly, and with the help of that, how we can access different large language model, and how we can build different kinds of application. I think you saw the ChatGPT, right? ChatGPT, like, it's a very powerful application. So if you, let's say, give any kinds of prompt, that particular prompt actually it will try to remember. Okay, then if you are asking the next prompt, it will also try to remember that prompt because it is using something called memory. Okay, memory inside ChatGPT, and how this memory is utilizing. So this concept is already available inside LangChain. LangChain is also having the memory functionality. So if you use this LangChain to implement this kinds of project, so you can also create a memory, okay, memory for that application, so that if user is giving any kinds of prompt, this prompt would be also remembered by your application. So not only that, actually it provides actually lots of functionality, guys. Unless and until you are not learning about LangChain, so you won't be able to understand. So what I will do, guys, let's quickly start our this practical demo of LangChain, because LangChain is all about practical. Here nothing theory is there. So I already prepared one amazing notebook for you, so there I will show you the entire LangChain demo. So guys, as you can see, this is the collab notebook I prepared. So first of all, let's connect this notebook. And make sure you select GPU, because going forward, actually we'll be using some open source large language model from the Hugging Face itself. And to use that one, you need a GPU based machine. Okay, so make sure you selected the GPU. If you're selecting CPU, it's completely fine. It will also work, but the execution time would be a little bit high. Okay, that is the thing. Now let me cancel. Now, if you want to see the official GitHub of LangChain, guys, this is so you can see this is the official GitHub of the LangChain. Okay, see, it's like very active research. The last commit was 3 hours ago only. Okay, now you can see they have given all the, let's say, tutorial how we can install and how we can access let's say different services of the LangChain. Everything they have given. Apart from that, see, they are having actually a very huge community. That means these are the communities supporting this library a lot. That means if anything is going wrong in this library, they're let's instantly solving that let's say issue. Even they're also upgrading this framework day by day. Now, apart from that, it is also having one beautiful documentation. So let me show you guys. This is the documentation link. If you just search LangChain documentation on Google, you will see this documentation. Now see, this is the entire documentation they are having. Okay, now see, different things they have developed. They have also developed ecosystem like LangSmith, LangGraph. We'll be also discussing about LangSmith and LangGraph. No need to worry. First of all, let's try to understand the fundamental of LangChain, like how we can install the LangChain, how we can integrate with different let's say platform. Like you can see, it is having different integration. Let me show you. So if I open the third-party integration, see, it supports Anthropic, then AWS, Google, Hugging Face, Microsoft, OpenAI, and many more. Okay, many more. See, all the different cloud Gen AI service it is also support. All the different let's say large language model platform it is support. Even you can also integrate with Hugging Face. That means whatever Hugging Face model I think I showed you now, I think you remember, all kinds of open source large language model is available inside Hugging Face. You can also easily use these at the model with the help of LangChain. And always try to remember, guys, LangChain doesn't have any kinds of large language model. Okay, LangChain is just a framework. It's just a framework to work with the generative AI based application with the help of large language model. Large language model wise, it will connect with different platforms. Let's say Hugging Face, let's say OpenAI, let's say AWS, let's say you can see different integration it is there. Let's say Microsoft. Okay, so those who actually provides these kinds of large language model, okay, so it can connect with those platform. This is the idea only. Got it? So it's just a framework. You can see they have also written LangChain is a framework for developing application powered by large language model LLM. Okay, I hope it is clear. Now see, they have written so many things. So what I did, guys, I just prepared one amazing notebook. So this notebook will give you the comprehensive idea how we can install and how we can use this LangChain. I think this is enough for you, okay, to learn about LangChain. Now see, this is the overview. So these are the things actually we'll be covering inside LangChain, like installation. We'll be learning about how we can like access different large language model. We'll be learning about prompt template, chains, agents and tool, memory, document loader, and indexes. Okay, so these are the things we'll be learning. Apart from that, we'll be learning some more advanced, let's say, technique. Like we'll be learning about ecosystem like LangSmith, LangGraph. Okay, these are the things also we'll be trying to cover. Now let's see how we can install the LangChain. So this is the command, guys, to install the LangChain. Just right pip install LangChain, and with that you need to install another package called LangChain community. Now let me install the LangChain. Okay, so after installing, I just need to set up some environment. like I need to set up my OpenAI API key as well as the Hugging Face API token. Okay, why? Because here I'll show you how we can use OpenAI. Okay, OpenAI large language model. If you want to use, let's say, any kinds of commercial model, how we can access it. Even I will also show you how we can access any kinds of open source large language model from the Hugging Face, let's say, hub. Okay, so for this I need to collect this authentication API. I think you know, or we have already generated one OpenAI API key. So see here, I have already written my OpenAI API key. So you can also write your OpenAI API key, and you need to also give the Hugging Face API token. And where you will get the Hugging Face API token, go to the Hugging Face platform, click on the profile, go to the settings. Now left hand side you will see access tokens. Now you need to create a token. For me, I already created the token, guys. You can see Langchain. Now if you want to create, just create a token, give the name. Let's say I'll give test. Okay, after that give the read permission and create the token. Now copy this token and try to mention it here. Okay, I hope it is clear. Now let me delete. I think I already created, so I don't need it. I will delete it. Okay, this token. So my token name is Langchain. You can give any kinds of name, it's up to you. Now let me set, these are the token inside my environment. Okay, it is giving one error because I have to initialize the operating system package first of all. Then let me set inside my environment variable. Okay, now what will happen whenever you will be using Langchain, now it will automatically load these are the API key from the environment itself. Okay, you don't need to manually set that. This is the idea. Now we'll be learning about how we can use any kinds of large language model with the help of Langchain. So I think we saw we are having like two kinds of large language model. One is like commercial model, one is like open source large language model. Okay, commercial wise we already saw the entire OpenAI platform. We are having GPT based model, and the open source wise we are having this Hugging Face model. That means we are having, let's say, Llama model, we are having Mistral model, Falcon model, like different models are available. Okay, in the Hugging Face hub, if you see, okay, there are thousands of like large language models are available. I think I showed you one platform, OpenLLM. Okay, it should be OpenLLM GitHub. Now list of all the OpenLLM. See, all kinds of large language model you can see, and these are actually open source large language model. Fine. Now, first of all, let's try to see how we can access actually OpenAI large language model. See, whenever I think I showed you the OpenAI platform and I showed you the demo of the, let's say, model, like if I want to access this model, if I want to give any kinds of prompts, so how we can do it. See, this OpenAI is already integrated inside Langchain. So I think I showed you the integration now. So this open source integration, just open it up. Now see, OpenAI is already integrated with Langchain. So you don't need to manually, so here you don't need to manually use the OpenAI platform like the way we used previously, like ChatCompletion API, completion API. No, you don't need to use like that. See, it's the very simple. First of all, install the OpenAI. Then just import from Langchain large language model. I want to use OpenAI. Okay, OpenAI platform. That means OpenAI large language model. Just try to import this particular class. Now here, just try to set the temperature parameter. Okay, temperature parameter. Now, what is temperature parameter? I think you remember. Temperature parameter, it's just a creative actually parameter. Like how much creative you want to be your large language model. You can see if it is 0, close to 0, that means temperature, it means the model is very safe and it is not taking any bits. That means it won't be taking any risk. Okay, it will stick to the output. And if it is close to 1, that means this will be taking risk. It might generate wrong output, but it's like very creative. Okay, I think I already explained this part. Now let me initialize my OpenAI wrapper. Now see, I have already initialized my OpenAI wrapper. Now see, this is my large language model. So guys, whenever you initialize this wrapper, by default, actually it will utilize one model called GPT 3.5 turbo model. Okay. But if you want to use any other model, you can give the model parameter here. There is a model parameter. With the help of that, you can also give any other model name. Okay, later on, I will show you how we can change the model. As of now, let's take the default model only. Now, let's say this is my prompt. You can see what would be a good company name for a company that makes colorful socks. Okay, this is the, let's say, my prompt I am giving to my large language model. Now, let me initialize this prompt. Now, see, if I want to, let's say, generate output, generate the response, I need to call the predict function. LLM.predict. Inside that, I need to give my prompt. Now see, it will give me the answer. Now rainbow threads or vibrant socks company. Okay, so this is suggesting the name of the company. Okay, that makes colorful socks. It's great. Now you can also directly pass this text to the large language model wrapper. So instead of calling the predict, you can also give like that. It will also work. So these are some actually way you can give the input to the large language model. Now see, it is also giving me the name. Now you can see, it has given me this name. Okay, this is the response. Now I can also use something called invoke function. Okay, inside invoke function also you can give the input. It will also work. See, Invoke has given some more detailed output. You can see it has suggested me different actually company. I can use this name. That makes actually colorful socks. Okay, it's pretty good. Now let me show you the second example. So I've written the same code, guys. You can see now here I've given another prompt. I want to open a restaurant for a Chinese food. Suggest me a fancy name for this. So now let me give. So it is suggest me Imperial Dragon Palace. Okay. Great. Now I can give the input like that also inside LLM object. Now Dragonfire Dining. Okay, great name. Now let me show you the Hugging Face. Okay, Hugging Face model, because see, at the end OpenAI is a chargeable. That means if you're sending any request to the OpenAI, okay, that means OpenAI model, it will charge you based on the token. So it's at the end there is a cost involvement. But let's say you don't want to spend the money, you don't want to use this kinds of paid model. You can also use open source large language model with the help of Langchain. It is also possible. For this, what you have to do, you have to use Hugging Face app. Okay, because inside Hugging Face I showed you, we are having lakhs of model. And all the models are open source. Okay, all the models are open source, and these are like large language model from the different organization. You can see from Meta, from Google, okay, from OpenAI. Then we are also having, see, OpenAI also having some kinds of actually free model. They are published in the Hugging Face. You can also use them. Mistral is also there. Different models. See, that many of models are available inside Hugging Face. It's like very used model, na? Even I also showed you different tasks you can select. Based on that also you can also select the model. It's up to you. Now let me show you how we can integrate Hugging Face platform and how we can access Hugging Face large language model also. For this you have to install one library called Hugging Face Hub. So let me install Hugging Face Hub. Because the models are available, it is present inside Hugging Face Hub. Because I already told you now, the model they have published, it is called Hub. Okay, Hub. Inside Hub, actually these models are present. Now see, I installed the Hugging Face Hub. Now let me import Hugging Face Hub from Langchain. Now see, this is the model actually I want to use. So I've already provided the link. Let me open. So this is called actually Flan T5 model. This is from Google. And this is one of the large language model, guys. You can see, if you are interested, you can go through the documentation. Okay. What can this model can perform and all, everything they have given. They have also given the paper link of the model. Now, if I go to my notebook, now see, here I'm using the large model. See, this is the extra large model and it's like very huge. I don't want to load this model. I want to use some smaller model because here I want to show you the quick demo. That's why. So I'm using this model actually, T5 large model. Let me show you. So this is the model, the same model only, but this is the small variant. This is the small variant and this is the X large variant. Like this is like more bigger than this one. Okay, I hope it is clear. Now, see, if I want to load the LLM object right now, that means large language model, I need to use Hugging Face Hub from Langchain. Inside that, I have to give the repo ID. That means the model you want to use, just copy the repo ID and pass it here. And you have to give some arguments. Okay, you have to give some model arguments. That means that same parameter, I think you remember temperature. What temperature will do? I think I already showed you. This is the creative parameter and the max length. I think you remember inside OpenAI also used to pass the max length. That means how many, let's say, output token you want to get from your large language model. So here I have given 64. Okay, you can increase and decrease as per your requirement. You can also remove this one. Okay, it's completely fine. Because at the end, it won't be charging you. Okay, it's a free model. So you can use as many of length you can. Okay. Now see, this large language model we are using, this is not like very good large language model, but somehow actually just to test, actually I'm using it. Going forward, we'll be using very powerful large language model, like we'll be using Llama model, Mistral model, Falcon model, okay, Gemini model. We'll be using different model. But this is like very basic large language model. Actually, I just wanted to show you as of now. Now this is the prompt I have given. Translate English to German. This particular sentence. Okay. Now see, how old are you? This sentence I want to do the translate operation English to German, and for this I'm going to use this model. Okay. Now let me execute and let me show you the magic. See, this is the output I got. This is the German translation of how are you? And this model actually it is trying to access with the help of Hugging Face API. Okay, Hugging Face API. That means the token you collected and I think you just set inside environment variable. With the help of that, it is sending the request to the Hugging Face. Hugging Face is returning the answer. Okay, we are accessing through API request right now. Going forward, we'll be also learning how we can download the model as well, and we'll be loading that model with the help of Langchain, and we can create a LLM wrapper and we can do the application building. Okay, so I'll also show you this part. No need to worry. As of now, I'm showing you the API access. Okay, if I only want to perform the inference operation, how we can perform it. That is the idea. Now, again, I've given the second example. The same example, I want to open a restaurant for Chinese food. Suggest me a fancy name for this. Again, I've initialized my LLM wrapper with the help of my Hugging Face model. Now, if I give this prompt to my large language model, see, it is giving me Chinese restaurant. So this is not actually creative RAM because I told you now I'm using very basic large language model, that's why. Okay, so yes guys, this is the introduction of Langchain. I think you got it. What is Langchain is and how we can use Langchain exactly. Okay, and it's like very easy to use, very easy to use. It will, trust me guys, it will make your task very easy. If you're using Langchain, it will make your task very easy. Okay, now in the next video we'll be learning about something called prompt template. Okay, like how we can create different prompt template and how we can pass to the, let's say, large language model, okay, with the help of Langchain. So previously, I think I showed you how we can use this Langchain to access different large language model. And whenever I was accessing this large language model, that means whenever I was, let's say, sending my prompt to the large language model, you can see I was giving the complete prompt. Okay, this is the complete prompt actually I was to pass. Let's say this is the prompt. I want to open a restaurant for Chinese food. Suggest me a fancy name for this. Now let's say if user needs to change this food, okay, food, let's say category, let's say he wants to, let's say, put Indian food here. So what he has to write again, he has to write the complete prompt, yes or no. That means if I show you, let's say I can copy and I can paste it here. Let's say I will comment this line. Now let's say here, instead of Chinese food, I will give Indian food. Okay, Indian food. Now if I execute, see, it is giving me Indian restaurant. Now let's say if I want to give any other food, let's say I want to give Korean food, I want to give, let's say, Pakistani food, I want to give, let's say, Italian food. So I have to every time write the entire prompt. Okay, but let's say you are creating a complete application. You are creating a complete, let's say, web application, or let's say Streamlit application, or any kinds of application. There you don't want to pass this entire prompt again and again, because if user let's say needs to pass this prompt entirely again and again, so it would be little bit actually, let's say, hard for the user, yes or no. Now see, instead of passing the entire prompt, you can see we can only change this food category. Okay, the food category will only change, otherwise see this prompt will remain same every time. So that time actually I can do the slight modification here. That means I can create a template of the prompt and user will only select that part he needs to change here. Okay, this is the idea. Now let me show you how it can be done. So for this actually we'll be using something called prompt template. Okay, now so inside Langchain we are having inside Langchain prompts we are having something called prompt template. Now here I've created a prompt template and here I've given the input variables is equal to cuisine. Now this is the same prompt I have written. You can see I want to open a restaurant for, now you can see in the bracket I have written cuisine. Okay, now this is going to be the input only and rest of the let's say prompt will remain same. Okay, as per the prompt you have written previously, suggest me a fancy food this. Okay, now here is the prompt template I'm creating. I'm just doing the format operation and cuisine is equal to Italian. That means user will only give the food category right now. Let's say Italian, Indian, Pakistani, okay, or let's say Bangladeshi, anything they can put here. It's up to them. Now user don't have to write the entire prompt. User will only change the food category here. Got it? So this is called actually prompt template. So whenever we'll be creating any kinds of let's say large language powered application, whenever we'll be creating any kinds of GenAI application, we always need to take care of this particular prompt. Let's say I don't need to pass the entire prompt. Instead of that, what I can give, I can only give the prompt which is required to get my output. Okay, this is the idea. Now see, if I execute this line, now see it is creating my complete prompt. That means user is giving Italian food. Now see, in the cuisine section it will come the now you can see in the cuisine section it will replace with the Italian. Now if I give, let's say, Indian, now see here it Indian will come. Okay, I think you got it. Now there is another way you can define this prompt template. Now you can write prompt template dot from underscore template. Now this is another prompt I have given. What is the good name for the company that makes? Now you can see product should be the input. Now here you can pass the product name like that. Prompt dot format product is equal to colorful socks or any other name. Let's say cakes or let's say biscuits. Anything you can give here. Now if I execute, see in the product this input would be replaced. Okay, so this is called actually prompt template inside Langchain, and this is like very powerful concept guys, because going forward whenever you will be implementing application, this concept will help you a lot. Got it? So yes, this is what I just wanted to show you. In the next video we'll be learning about chains inside Langchain, and with the help of chain actually we'll be integrating this prompt template as well as the large language model, and we'll be again doing the inference operation. And what is the use of prompt template? I already explained. Now see, if I want to use this prompt template with my large language model, so what I have to do, I have to combine my large language model as well as the prompt template I have created. Okay, for this we'll be using something called chains. You can see combine LLMs and prompt in a multi-steps workflows. Okay, to create a multi-step workflows, I have to create a chains. Now let me show you one example. I think then this part would be clear. Let's say first of all I will initialize my large language model wrapper, and here I'm using OpenAI model. Now see, previously, I think you remember, we learned this prompt template. That means if I want to, let's say, give any kinds of prompt, but I don't need to pass the entire prompt, only I want to pass some specific, let's say, point of that particular prompt. You can see here, only I want to change the product name. So for this, I created a prompt template, and the product name, I've given the colorful socks. Okay, this is my entire prompt. You can see now it will create my entire prompt. So which is the good name for the company that makes colorful socks. That means whatever input you are giving, it will replace it here. Fine. Now, as of now, let me comment this line. Let's say this is the prompt I have created. This is the entire prompt I have created. I think you would remember. Now, if I want to use this prompt, the prompt template I have created with my large language model, I have to use something called LLM chain. And how to import LLM chain? So from Langchain.chains, import LLM chain. Now, the first parameter you have to give the large language model. The large language model you have defined, which is nothing but Open AI large language model. You can also use open source large language model. You can use Hugging Face large language model as well, the way I showed you. Then you have to give the prompt template. The second parameter is, you can see prompt is equal to prompt. That means the prompt template I have created, this object actually I'm passing here. Then just try to call this function chain.run, and inside that give the input. Let's say whatever input you used to give like that. Instead of giving, you have to give chain.run and give the input. Let's say colorful socks. Now if I execute, see, it will give me the output. See, rainbow threads or chroma shocks, I think. Okay, chroma shocks, actually, it is giving me the output. That means now we are able to use our prompt template as well as the, let's say, LLM. Okay. And for this, we are using something called LLM chain. That means, first of all, it is creating the entire prompt template. First of all, it is creating the entire prompt template. That means this entire prompt template, if I show you, that means it is first of all creating the entire prompt template, and this prompt actually it is passing to the large language model. And how things are happening with the help of LLM chain. Okay, that's why here I have written with multi-step workflows. That means it is creating a workflow in the backend. It is creating a pipeline. So first of all, it will create the prompt, then this prompt would be passed to the large language model, and these things are handling by the LLM chain. I think you know what is chain, na? Chain means like one, let's say, chain would be connected with another one. Okay, that means complete pipeline, complete workflow, sequence of, you can say, chains. Okay, so I think now you got it, what is chains exactly inside LangChain. Now let me show you another example, example 2. So again, I'll initialize my large language model, and see, now here I'm using the second approach. I think, remember, we can also create the prompt template like that. So let's say here input variable is nothing but my cuisine. That means cuisine will only change and rest of the prompt will remain same. Okay, now this is my prompt template. Now if I want to pass this prompt template to my large language model, what I will do, I'll use the LLM chain. Inside LLM chain, I'll first of all give the LLM, then I will pass my prompt template, the prompt template I have created. Now you can see I'm calling chain.run, and here I'm giving the input. Let's say Mexican. I want to see the Mexican. Now here you can see I've given Mexican as an input. That means I want to open a restaurant for the Mexican food. Now if I execute, so it should suggest me some fancy name for this. See, this is the name it has suggested me, El Sober de Mexico. Okay, the flavor of Mexico. Now if you want to see internally how it is like creating the entire prompt, for this you can activate one parameter called verbose is equal to true. Now see, if I again execute, it will show you, see, internally first of all it will create the complete prompt template. That means here you have given Mexican, so it will first of all create the complete prompt template with the help of Mexican. This prompt template will be passed to my large language model, and large language model will give you the output. Got it? So this is the work of chains. Now this is called actually single chains. Now let's see if I want to create a multiple chain. That means, let's say you want to create a chain, and this chain output you want to again pass to another chain. Okay, for this you can use something called multiple chain. Okay, multi-chain. And to use the multi-chain, you have to use something called simple sequence chain. So there is another class inside LangChain chain called simple sequential chain. We'll be using this one. Let me show you one example. Let's say this is my large language model I have defined, and this is the prompt I have created. The first prompt, you can see the same prompt. I want to open a restaurant for the cuisine's food. Suggest me a fancy food name for this. So it will take the cuisine input, and this is the LLM chain I have created. Okay, I think you remember, this is the LLM chain I have created. That means this is my LLM wrapper, and this is my prompt template. Okay, now what I want, whatever, let's say, restaurant name actually it will suggest. Okay, whatever restaurant name this prompt will suggest, that means this large language model will suggest. This name again I want to pass to another prompt template. For this I created another prompt template. Now input variable is restaurant name. That means this prompt will give you the restaurant name, yes or no, because here you have given cuisine's food, suggest me a fancy name for this. Okay, now it will give you restaurant name, and this restaurant name I want to utilize, and here I have written another prompt, suggest me some menu item for this restaurant name. That means, let's say you have given Indian, let's say, food. Now it will give you some Indian restaurant name, and this Indian restaurant name here I will pass, and it will give me some menu item for the Indian restaurant name. Okay, I think you got it, how it is interconnected with each other. This is called actually multiple chain. Okay, now see here, I've created another chain. Now if you want to use this both chain, I have to use something called simple sequential chain. Now there are some limitation inside simple sequential chain. I'll tell you what is the limitation. As of now, let me show you the, let's say, example. So you can see I have initialized the simple sequential chain. Inside that chain is equal to, first of all, I will give my name chain. You can see, first of all, I will give my name chain. That means it will give me the restaurant name. Okay. Then I will give my food item chain. That means this particular chain. That means whatever restaurant name I will be getting from this chain, I want to pass to the next chain. Okay. Which is nothing but my suggest me some menu items for the restaurant name. Okay. Now, here is the final code, chain.run. Here I have given the Indian. That means first of all, it will go inside that and it will give the output, and this output will go in the next chain. Okay. Now it will give me the output. Let me show you. Now see, I have given Indian. Now see, this is the Indian menu I got. That means what is happening? First of all, it is executing this prompt template. Then it is executing this prompt template. Okay. And how it is handling? It is handling by the simple sequential prompt template. That means it is following the sequence. First of all, this sequence will execute. Then this sequence will execute. That's how we can create multiple prompts. Not only 2 prompts, you can create 3, 4, 5, 6, and so on. If you need any kinds of, let's say, application, this is like interconnected with, let's say, previous prompt. Okay, you can create this kinds of sequential prompt. Now I think you got the idea how ChatGPT works. Okay, how ChatGPT works. Let's say how, let's say if you are giving any kinds of input, how it is connected with the previous prompt as well. Okay, they are also using something called this sequential chain in the backend. Okay, chain method they are also using. I think it is clear now. Now the limitation of simple sequential chain is it is only showing you the last output, last chain output. You can see only the menu item. But if I want to also see the previous chain output, what is the output it is giving? For this, you have to use something called sequential chain only. Okay, sequential chain, not the simple sequential chain. Okay, this is the difference only. Now let me show you one example. Let's say I've given the same example. So I want to open a restaurant cuisine name. Okay, here I have to pass, and here creating the LLM chain. Okay, now this is the another chain I've created, guys. You can see. So whatever, let's say, restaurant name actually I will get from my first chain. So you can see output key, it will return you the restaurant name. So it should be the input for the next chain, which is nothing but my menu. Okay, menu of the restaurant name. Here you given the input is equal to restaurant name, and this is the template. Suggest me the menu of the item for restaurant name, and this is my second actually chain I have created. And what is the output of this chain? The output would be menu item. That means whatever menu actually it will suggest you. Now here I have initialized my sequential chain. Now inside sequential chain, I have to pass my chain. First of all, I have to give my name chain. That means the first chain I have created. Then I have to give the second chain. Now here you have to specify the input variable. What is the input variable? I think you saw the first input variable is nothing but cuisine. Okay, cuisine should be my input variable. And what will be the output variable? Output variable would be the restaurant name as well as the menu item. Okay, restaurant name as well as the menu item. That means both it will show me. Now let me execute and let me show you. See, now I'll call my chain, and here I will give the input only, which is nothing but Indian. That means cuisine name. Now see, it will give you the output. See, first of all, it will give you the cuisine, then the restaurant name as well as the menu item. That means this prompt, it is giving you the output. This prompt, it is giving you the output. Even the menu item, it is also giving you the output. That means complete output you can see here. So which is not available inside my simple sequential chain. Okay, this is the difference only. I think you got it right now. Got it? So yes, that's how actually we can use chain to interconnect my prompt template with my large language model, and we can easily get any kinds of response from my LLM. Okay, now in the next video we'll be learning about something called agents and tool inside Langchain. So what is agents and tool exactly? Let me show you. See, agents and tools is actually a very powerful concept inside Langchain. So it will help you to, let's say, plug in with different kinds of, let's say, tool. Let's say if I give you one example, let's say I have traveled from Dubai to Canada. I type this in ChatGPT. Now give me 2 flight option from Dubai to Canada on September 1, 2024. Now ChatGPT will not be able to give the answer because it has actually knowledge till September 2021. That means after 2021, if you are asking anything to the ChatGPT, it won't be able to give the answer because it doesn't have like the new information regarding 2024. But ChatGPT Plus has Expedia plugin. If we enable this plugin, it will go to the Expedia plugin, and it will try to pull the information about flights, and it will show the information. That means if it is not able to give the answer related to 2024, what it will do, it will try to connect some third-party plugins, third-party API. Okay, and from there actually it will pull the information and it will show you. Let me show you one example. Let's say this is my ChatGPT. Now here, if I give this prompt, what was the GDP of Canada in 2024? Now see, if I give this to the ChatGPT, see, ChatGPT is searching Canada GPT. See, it is already searching. Okay, it is already searching in the third-party API. Now see, in 2024, now you can see it has given me the answer in 2024. What was the GDP? Okay, in that Canada. That means it doesn't have the information about, let's say, 2024. What is the Canada GDP? But it was searching. Okay, it was searching in the third-party API. That means it has some plugins inside that. Okay, so it is happening with the help of this agents only, agents and tool. Okay, with the help of agents and tool, they are doing this kinds of tasks. Now let me show you how you can also perform this agents and tool operation inside LangChain. Let's say you want to create an application, and this application will also be able to give the answer from the newest, actually, let's say information, okay, over the internet. For this, you can connect actually different tools, different plugins. You can connect SARP API. See, this is the SARP API. SARP API is a Google search, actually, let's say API. You can also directly search from the Google. Even you can also connect the Wikipedia. Okay, let me show you one Wikipedia example. Even you can also connect different actually third-party plugins. Okay, there are so many third-party plugins. If you search on Google, you will see different third-party plugins they are using. Okay, you can also connect it to weather. Okay, weather API to get the, let's say, recent weather. It is also possible. Now see, first of all, I will be installing Wikipedia just to show you the demo of the Wikipedia. Now you can see I'm importing these agents from the LangChain. I'm importing agents type, then initialize agents and load tools and all. Then I'm also importing my OpenAI. That means I want to use OpenAI large language model as of now. Now this is my, let's say, LLM wrapper. Okay. Now if you want to define the agents, so you have to define like that, guys. First of all, call this load tools, and inside that, first of all, mention which, let's say, plugins you want to use. I want to use Wikipedia plugins. That means whatever things actually I'll be searching, if it is not available inside my ChatGPT, let's say knowledge base, it will go to the Wikipedia. Okay, it will hit the Wikipedia, and from Wikipedia actually it will get the response. Then it will also use something called LLM math tool. And why LLM math tool? Because let's say if you are asking something related GDP, or let's say any kinds of number, any kinds of numerical representation. So for this, actually this LLM math is required. Okay, they are suggesting if you go to the documentation, you will see that. Then I'm also passing my LLM wrapper, this particular object. Okay, that will give me the tool. Now here I have to initialize the agents. First of all, give the tool you have created, then give the LLM you have created, as well as the agent type. So this is the agent type you can give, and verbose is equal to true means it will also show you the output. Okay, like what it is executing in the backend. Now just simply search agent.run. What was the GDP of US in 2024? Let's say this is my question. 2024 GDP I want to ask. Okay. Now see, if I execute this program, now see, it has actually connected with my Wikipedia, and it has fetched the information, and this is the final result, guys. You can see the GDP of US in 2024 was 28.269 trillion dollar. Okay, it's great. That means it is also able to get the current information, okay, newest information over from the internet itself. And this is like very powerful tool, guys. Trust me, if you want to implement any kinds of let's say LLM powered application, and you want to integrate this kinds of functionality, you can use this agents. Okay, because ChatGPT is also using agents in the backend. I hope it is clear. Okay, now in the next video we'll be also learning about memory. Let's say I told you now ChatGPT can also remember the previous context. Let's say if I give one let's say message here, give me a code to add 2 numbers in Python. Let's say this is the prompt I have given. Now see, it has given me the code. Now see, it has given me one function, but I don't need the function. I'll just write without function. Now see, it has automatically remembered my previous prompt I have given, and now see, beautifully it has given me the second response. That means it is having some memory, okay, a buffer memory in the backend. With the help of that, actually, it is trying to remember my previous context. So we'll be learning this part in the memory part. I think I already showed you one demo of the ChatGPT. ChatGPT can remember my previous, let's say, prompt. That means whatever previous prompt you are giving, it can remember that context, right? So how they're remembering the previous, let's say, prompt and context? Because they're using something called memory, okay, memory in their application. Now, with the help of LangChain, actually, we can create this memory. So whenever you want to create any kinds of generative AI applications, so definitely you should integrate the memory with that, because people will be asking the question and your application should remember that particular context. Okay, this is the important things. Now let me show you one demo of the memory. So here I've already written chatbot application like ChatGPT. You will notice it will remember the past information, and how they are remembering the past information, they're using memory. So let me first of all initialize my LLM wrapper. I'm using the OpenAI LLM here. Now, first of all, let me show you, if you are not using like memory, okay, memory, let's say functionality from the Langchain, what will happen? Let's say here I've created a prompt template, the same prompt template. I want to open a restaurant for the cuisines food. Suggest me a fancy name for this. Now see if I create this prompt template, and if I give this prompt template, what I have to do, I have to use LLM chain. Here I'm passing the LLM, and here I'm giving the prompt template. Okay. Now this is the, let's say, input I've given Mexican. So it will give me the output, the restaurant name. So guys, you can see it has suggested me different restaurant name. Now, if I give Indian also, see, it has also given me Indian restaurant name. Now, if I show you the chain memory, that means whether it has saved anything or not. So I'll just write chain.memory. See, it is none type. That means it hasn't saved my previous information. Whatever, let's say, question I have asked, it hasn't saved any kinds of information. Okay, you can see it's a none type. Completely, it's a none type. Now, if I want to add the memory functionality, what I can do, I can use actually 3 kinds of memory inside Langchain. I'll discuss all of them one by one. First of all, let's try to see conversation buffer memory. Okay, so just try to import Langchain.memory, import conversation buffer memory. Okay, now see, this memory will try to remember the previous conversation. Now, first of all, create a memory object. You can see conversation buffer memory object. Now, same thing you have to initialize, only another parameter you have to pass, memory is equal to memory. Okay, now again, I'm giving Mexican food. Now I have given, let's say, Arabic food. Okay, now if I show you my chain.memory.buffer, you will see that it has remembered my previous context. So if human has given Mexican, then AI has replied. Again, human has given the, let's say, Arabic input, then again my agent has replied. That means it is trying to remember my previous conversation. Amazing, right? Now, one issue actually will get with this conversation buffer memory, it can remember all the input it will be giving. Let's say whatever input it will be giving, all the input actually it will try to remember. So whenever it is trying to remember all the input, that means it is occupying your memory space. So I don't need to remember all the, let's say, context of the user. I can only remember, let's say, 5 to 10, let's say, context. It would be enough for me, because if you go to the ChatGPT also, it can only remember 5 to, let's say, 6, let's say, context, 5 to 6 conversation. Okay, apart from that, whatever things it will say previously, it will delete. Okay, so for this, actually, we can use another actually memory called conversation chain. Okay, now here I have already written conversation buffer memory goes growing endlessly. That means it can save all the information. And if I want to set only, let's say, 5 conversation, or let's say 10 to 20 conversation, that time I will be using conversation chain. Now here is the example of conversation chain. First of all, you have to define the conversation chain, and inside that you have to pass your LLM wrapper. Now let me show you the template. Now see, this is the template actually it will give you. Okay, now you can see current conversation, there is no conversation, that's why it's empty. Now let me do some conversation. So here I have given the first conversation, who won the first cricket World Cup. Let's say this is my first conversation. So this is the output I am getting. You can see the first cricket World Cup owned by the India in 1983. Okay, now here I will give another, let's say, prompt. How much is 5 plus 5? See, this is the irrelevant question I'm asking. Now this 5 plus 5 is equal to 10. Now again I'm asking who was the captain of the winning team. Now it will refer my this actually prompt. Okay, this context. Now see, the captain of the winning team in India was Kapil Dev. Do you have any other question? See, amazingly, it has remembered my previous let's say conversation. Okay, that's how also ChatGPT is working. I think the same example I have given you. You can also ask this question like this add number code question. You will also see the same output. Okay. Now if I show you the my buffer memory right now, so this was my input, then this was my like model output. Again I asked this question, again this was the output, again I asked this question, this is the output. Okay, that's how actually you can save 5 to 10 conversation here. Okay, 5 to 10 conversation here. After that it will remove everything. Okay, now you can also set the window size, like how many conversation you want to save. You also have one parameter to set. For this you have to use something called conversation buffer memory window. Sorry, conversation buffer window memory. Now just try to define the memory. Inside that just mention this parameter k is equal to 1. That means it will only remember one conversation. Okay, now just try to define this conversation chain. Inside that mention your LLM as well as the memory. Now if I again do the conversation, who won the first cricket World Cup, now I'll again ask how much is 5 plus 5. Now it is giving me the output. Now again, if I ask who was the captain of the winning team, now see, it is telling I don't have enough information, context, answer this question. Okay, because I have only given k is equal to 1, that means it is only saving my one information. Okay, now if I give, let's say k is equal to 3, now it will remember my previous three conversation. Let me show you. Now again, if I ask this question, who was the captain of winning team? Now see guys, it is giving me the output. Okay, now if I show you the conversation, now you can see it is remembering my previous context. Got it? So that's how whenever you are creating any kinds of application, guys, try to use this memory. Okay, memory inside your application. This will make your application very powerful. And now I think you are getting the logic behind ChatGPT, how ChatGPT is working. It's just an application, guys. Always try to remember ChatGPT is an application. Inside that, they're using large language model, which is nothing but GPT series. Okay, and whatever functionality they have created, this memory functionality, then chain functionality, prompt template functionality, they're using this kinds of framework, Langchain framework or LlamaIndex framework. There is another framework called LlamaIndex. This is the alternative framework of Langchain. We'll be also discussing this part as well. Fine. Okay, great. Now in the next video, we'll be learning about documents loader. Let's say whenever you want to build any kinds of RAG-based application, retrieval augmented generation, let's say you have some custom documents, and if you want to load these documents and you want to connect with your, let's say, large language model, that time you have to load your documents. Okay, whatever documents you are having, whether it's a PDF documents, documents, or let's say TXT documents. Even you can also load the website also, just on any kinds of file format you can open, any kinds of website you can integrate here. Okay, so Langchain is very powerful, guys. You will be loving a lot, trust me, guys. So in the next video, we'll be learning how we can load the documents. Then after learning this, Langchain will be also implementing different projects, so that this concept would be clear, how we can load our custom documents, how we can create a RAG-based application, okay, how we can create a chatbot, different things we'll be learning. So if you go to the Langchain documentation, you will see we can also load different documents with the help of Langchain. So you can load, let's say, custom documents, let's say any kinds of file format, CSV, then a file directory, HTML, JSON, Markdown, okay, Microsoft Office, PDF, text splitter, okay, any kinds of documents you can load with the help of this Langchain. Even you can also connect different, let's say, platform. You can also connect Slack. You can also connect, let's say, Discord. And from there also you can extract the data. It's like very powerful, guys. You can go through the documentation. You will get each and every idea. Even they have also given the code snippet. Okay, how we can, let's say, connect with different, let's say, document format, and how we can load the documents. Fine. See, always try to remember, whatever, let's say, data we are loading inside Langchain, it would be considered as a document. Let me show you one example. So here, let's say I want to load one PDF documents. Let's say PDF I want to load. Let's say I'm having one PDF. Let me show you. So this is my research paper, guys. This is my research paper, guys. I published some years back. You can see I'm the author. So this is the author. Okay, I'm the author. Now you can see this paper is about actually development of multiple combined regression method for the rainfall measurement. Okay, and this paper is already published in the ResearchGate. Let me show you. If you go to my LinkedIn profile, this is my LinkedIn profile. You can connect me on LinkedIn, guys. You can follow me. So if you have any question, you can ask me there. I'll try to reply. Now see, if I show you this particular publication, so see, this is what I've already added. Now if I open this publication, see, this is the publication, and this is in the ResearchGate. Okay, even if you open the Google Scholar also, you will get it there. So this PDF actually I have downloaded, this paper PDF I have downloaded. Now what I will do, I'll just try to load the documents. Okay, whatever, let's say, information I'm having in this, let's say, PDF, I want to extract these are the information. For this, I'll be using Langchain. So let me show you. First of all, I need to install one package called PyPDF. Now let me upload that PDF here. So my paper, I'll upload it here. Now see, it is getting uploaded. You can use any kinds of documents, guys, docs, TXT, CSV, JSON, anything. And again, visit the documentation, you will get all the code snippet. Let's say you want to use JSON. So this is the JSON, okay, JSON loader you have to use. Let's say you want to load CSV. You have to use CSV loader for this, okay. Now I'll be loading something called PDF. That's why I'll be using PDF loader. Okay, now see, this is updated. Now I'm importing this PDF loader from Langchain. You can see document loader, PDF loader. Now here you have to give the location of the file. Let's say this is my location. Okay, now you have to call loader.load. Now see, it will automatically extract all the information. And this data would be considered as a document. Let me show you. Always try to remember, inside Langchain, inside Generative AI, all the data would be considered as a documents. Okay, that's why I think you remember in the vector database session, I was talking about documents. Okay, chunking documents, these are the thing. Okay, now I think you got it. Now see, it has extracted all the pages. Now see, this is considering as a document. This is the type of documents right now, and all the information present inside my paper. Got it? Now we can use this data To implement any kinds of RAG based application. That means with the help of vector database, I can store these are the data with the help of embeddings, and I can connect my large language model and I can ask some information there. Okay, don't need to worry, I'll be explaining this RAG concept and all. Okay, why RAG is important, why we have to create the RAG. Even we'll be also learning about fine tuning. Okay, how we can, let's say, take our custom data and we can perform the fine tuning. As of now, we have learned the fundamentals of LangChain, and I think I covered almost everything about the LangChain, whatever things you need to work with the LangChain. But I will show you some more advanced concept of the LangChain. This will also help you. Okay, so far I think we have covered so many things inside LangChain. We have learned the entire fundamental concept of the LangChain. So one thing I wanted to tell you, see, LangChain also can work with this your pandas data frame. That means directly pandas data frame you can pass to the large language model, and you can ask some question there. Okay, it is also possible for this. You can use your large language model, any kinds of large language model, and with the help of LangChain framework, you can perform these kinds of operation. Let me show you. So first of all, I have to install some of the library. So here you can see I'm installing LangChain and LangChain experimental. Why LangChain experimental? Because this pandas data frame actually agents will be using. This is available inside LangChain experimental. Okay, that's why I have to import all of them. So let me import. And I'm going to use OpenAI large language model. That's why I'm using OpenAI here. Now I'm going to import some of the required libraries I need. Now you can see from LangChain experimental agents toolkits, I'm importing create pandas data frame agents. Okay, you can go to the documentation. You can see pandas data frame documentation inside LangChain, and they're also loading in that way. Okay, and they're giving a data set. Okay, any kinds of data set they're loading with the help of pandas, and they're performing lots of operation. Okay, so you can use different large language model, and you can perform chat operation. Okay, with this data frame. Let me show you. So let me import the library first of all. I'll import the pandas as well. I'll set my OpenAI API key. Then this is the data I want to load. Let's say this is the CSV data, Titanic CSV data. It is available in this GitHub. If I show you the live GitHub link. So this is the data, guys. It is already available. So let me first of all load this data with the help of pandas. So here is the data, guys. I think you are already familiar with this Titanic data. Now, first of all, we'll be performing this chat operation with the single data frame. So I'll initialize my large language model. Now create agents. To create agents, just call this create pandas data frame agents, this class. Inside that, give the LLM data frame. Verbose is equal to true means it will show you the entire, let's say, execution details. And here you have to give another parameter called allow dangerous code is equal to true. Now I'll create the agents. Now here I can ask the question right now. I'll ask how many rows are there in the, let's say, data frame. Now see, it will count and it will automatically give me the answer. See, around 891 rows are available. I will give another question. How many people have more than 23 ages? See, amazingly, your model will try to go through that data frame and it will give you the answer. See, 468. Now I can also work with multi-data frame. So for this, what I can do, I can copy this data in another variable called df1. See, I'm copying this df only. Now I'm creating another df1 here. This is the data. Now what I will do, I'll just fill the none value, okay, which is present inside age, because age is having some none value. I'm just filling. Now again, I'm creating the agents. You can see. Now here you can see I'm giving multi-data frame, df and df1. Okay. Now let me create the agents. Now I'll ask one question. How many rows in the ages columns are different? Okay. Now let me show you. Because I already filled the information. Around 177 rows have the null value. Now you can see rows have different values in the age column. I think you got it. Now I'll create another data frame called df2. And now I will just multiply 2 with the age. Whatever age I'm having, I'm just multiplying 2. Now this is the results. Now I'll create another agents and it will have 3 different data frame. Okay. Now let me create the agents. Now I'll ask one question. Are the 3 of the columns same in all the data frames or not? Definitely it should be same for all the data frame because I have just copy pasted the same data frame again and again 3 times. So here all the column name should be same. If I show you the output, see. So see guys, I'm getting the output agent stopped due to the iteration limit or time limit because I'm executing multiple time now. That's why I just use the limit. Okay, that means my limit has been done. So what you can restart the runtime again. You can execute the entire code. You will see that all the column should be same. Okay, in 3 different data frame. Okay, we'll get this kinds of output. Now you can ask any kinds of question. Okay, about this data frame. So this is called actually multi-data frame agents inside Langchain. And this like again very powerful concept if you want to work with the data frame and all. Going forward, we'll be also implementing some projects with that. Okay, this concept will help you a lot. So as of now, I think I showed you lots of example, lots of demo of the Langchain, like what are the things we can perform. Even I also told you we can also, let's say, access different open source large language model from the Hugging Face itself. Okay, so this would be the dedicated video about this Langchain integration with the Hugging Face. So there I will see that how we can access different model with two kinds of method. Like one method I will show you how we can access through the API request. Another method I will tell you how we can download the model, okay, in our Google Colab, and how we can use this particular model. Okay, this is the idea. So first of all, let me install some required package. So you can see I'm installing Langchain community, Hugging Face app, Transformer. Why Transformer? Because I want to use a Hugging Face platform. I want to download the Hugging Face model. That's why Transformer is required. I think I already taught you about the Hugging Face, like how to use Hugging Face and what is Transformer library, everything I already discussed. And these are some actually dependency package you need to also install with the Hugging Face. That means your Transformer. Now let me install all the library one by one. So guys, as you can see, my installation is completed. Now let's import some of the library. You can see I'm importing prompt template, Hugging Face app, LLM chain from the Langchain itself. Now, first thing what you have to do, you have to setting up the environment. For this, you have to set the Hugging Face API token. And how to get the Hugging Face API token, I think I already explained. Go to the settings, and left hand side you will see access token option. So you can create a new token here. I already showed you how to create a token. Okay, so I'm not going to show you again. So now let me set my token. Now we'll be learning the first approach, like access the hosted model on Hugging Face through API request. Okay, now see, here we'll be accessing one text to text generation model. So first of all, let's create a prompt template. So here's the prompt template I have prepared. What is the good name for a company that makes product? So product should be my input here. Now here I'm creating the LLM chain. I'm giving my large language model, and you can see I'm using Hugging Face app, and I'm giving this model ID. That means I will be using this model. So this is the FLAN T5 model. This is from Google actually. So we'll be using this model here. So let me load this model, and here is the model arguments. That means temperature and max length parameter, and here I'm giving the prompt. Okay, the prompt template I've created. Now let me create the chain object. Now here you can give the output. Let's say I will give colorful socks. Let's see whether it is able to give the response or not. See, it has given me sock mania. Okay, this should be the name. Now let me show you another prompt. You can see I have written another prompt. Can you tell me about famous footballer? So it will take the famous footballer name, and it will tell you about him. So let me show you. So again, I'll create the chain and see the same code actually I'm using. Now if I give Messi, now you can see guys, it is giving me the response. Messi is a footballer who plays for Argentina. Great. Now you can give another prompt. Let's say, can you tell me food items for the cuisines restaurant? So cuisine should be the input. Let's create. And I'm using the same code snippet. Now let me initialize the chain and let me give the input. Let's say Indian. Now see, it is giving me vegetable. Okay. Can you tell me the food items? Yeah, vegetable is fine. Now if I again execute, let's see. Okay, vegetable it is giving, because I told you this model is not good. Now guys, let's see how we can use any other model. See, again I have prepared one prompt template, and again I'm using the same thing. Can you please tell me about famous footballer? Now see, instead of this T5 model, I'm using Falcon 7B. So this is one of the large language model. It is already available in the Hugging Face. Okay, you can see. So this is the organization, they published this Falcon, and Falcon is having different variant. Falcon 7B, 13B. Okay, that's how it is having different variant. And this is one of the like great large language model you can use. Now let me show you one demo. Now let's load it, and see, I'm using the same code snippet, and I'm sending the request. See, this model actually I'm not downloading in my machine. So it is using the API to access the model, and it is giving me the response, and that response actually I can see. Okay. Now see, this is the response I got, and it's like very detailed response I got. Okay, than your previous response. Now let's see the approach to like how we can download this model locally and how we can create a pipeline. That means that Hugging Face pipeline, I think, remember, right? For this, let's import Hugging Face pipeline from Langchain. Then I'm also importing some additional library like auto tokenizer, auto model for casual LM, then pipeline. Okay, these are the thing I'm importing because I think you remember how to create the pipeline. So let me import them. Now see, I'm using this FLAN T5 model again. So let's initialize the model. And first of all, I have to create the tokenizer. If I want to download the model, I have to create a tokenizer. I think you know that, right? Tokenizer will pre-process your input. That means it will process input. It will create the embeddings, and then it will pass to the model. Now here, I'm going to initialize my model. You can see I'm giving the model ID. Then device map is equal to auto. That means it will load the model inside my GPU. And make sure whenever you are like downloading the model locally, you are using GPU based machine. Okay, good configuration machine. Otherwise, execution time would be very like slow. Okay, but if you're accessing through API, you don't need a GPU based machine. Now let's create a pipeline. You can see it's a text to text generation model. So here I've given text to text generation model, tokenizer, and max length. Now let me create the pipeline. Now I'm going to initialize my LLM wrapper. So I think you remember we called this Hugging Face pipeline from Langchain. Now, so here you can see I have initialized my LLM wrapper and pipeline. The pipeline object I'm getting, I'm passing inside this Hugging Face pipeline. Now this is going to be my wrapper. Now again, I'm going to create the prompt template, and this is the example I have taken, the same company. Okay, company example. Now let me pass to the LLM chain and as well as my prompt. See, I'm passing my large language model as well as my prompt. And now see, the model actually I'm passing, this model actually I've downloaded. Okay, LLM, local LLM, not the API one. Okay, so both way you can use this Hugging Face. Now let me show you the results. See, Socks Mania. Now let me prepare another prompt. Can you tell me about famous footballer? Now let me initialize the chain. Now let me ask about Messi. See, Messi is a footballer who plays for the Argentina. Okay, so that's why, guys, we can access Hugging Face model, open source large language model with the help of Langchain. And going forward, we'll be using this concept, guys. And with this concept, we'll be implementing so many applications. So this project will be implementing with the help of whatever things we have learned so far. Let's say Langchain, large language model, vector database. Okay. Even we'll be also implementing one front-end application of this project. That means user will get one user interface, and their user will upload the data, and they will get the results. Okay, so these kinds of things actually will be also implementing. That means I'm going to show you the complete project structure here. That means we'll be doing modular coding here. But before that, I'll show you the notebook experiment, like how we can implement this project through the Jupyter notebook. Then I'll try to convert this Jupyter notebook to the end-to-end manner. Okay. So I think you saw the name interview question creator. I think you are already getting what is the project about. Interview question creator means, let's say you are having one PDF documents, or let's say any kinds of documents, whether it's a docs documents, PDF documents, TXT documents, or whether it's a books. Okay. So what you have to do, you just need to upload that, let's say PDF to this application. And this application will automatically generate the questions. Okay. Question as well as the answer. Okay. Of the topic actually will be giving. Let's say you have uploaded one Python PDF here. So this application will generate some Python questions, interview questions, as well as the answer. Okay. And that question and answer you can use, let's say for your candidate, or let's say you are a teacher and you want to generate interview questions, or let's say exam questions. What you can do, you can use this application to generate this kinds of question and answer. So it would be very easy for you to generate this kinds of question. Otherwise you have to manually find the questions, manually, let's say, prepare the answer. So it will take time. But if you are creating this kinds of application, it will help you a lot, okay, to automate your process. Again, it seems like a simple project, but whenever you will be implementing, you will get the complexity. And this is like very interesting project because this is the first project I should be implementing after learning Langchain. Going forward, we'll be also implementing some advanced projects, like we'll be implementing medical chatbot, source code analysis. Okay, so these are the things we'll be also implementing. So instead of talking too much, guys, let's start the implementation. But before that, I will show you the, let's say, the requirements actually I need to implement this project, and I will also show you the project architecture. So guys, to implement this project, I need some requirements. Okay, I need some requirements. So here we'll be using Langchain to implement the entire, let's say, project. And why Langchain, I think you know, because Langchain having all the functionality, right? Let's say you want to integrate vector database, you want to integrate large language model. Okay, everything is available here. So that's why we'll be using the complete Langchain here. And large language model wise, we'll be using OpenAI model. OpenAI will be using GPT 3.5. Okay, this model actually will be using. Going forward, we'll be also learning how we can use open source large language model. With the help of that, I will also show you how we can create the application. Now, third, I need vector database, vectorDB. So here we'll be using Fies. Okay, so Fies is another actually vector database. I think I haven't covered in my vector database series. So that's why I thought let's also show you this Fies in this video, so that you will be also learning about Fies. So Fies has implemented by Facebook AI, and this is one of the vector database. This is the local vector database, actually local vector database. So you have to set up everything in local machine. Going forward, we'll be also using Pinecone, Weaviate. Okay, no need to worry.
Then to implement the entire, let's say, front-end part of our application, that means we'll be creating the user interface with the help of Fast API. Fast API. I think you know what is Fast API. Fast API is a Python framework. With the help of Fast API, we can create a user interface web application. Apart from Fast API, we're having, let's say, Streamlit, Flask, Django, okay, Falcon. So these are the things you can also use. We'll be exploring one by one all of them. I think we saw the Flask previously. I think remember Flask. I think I showed you. We created some of the application with the help of OpenAI. We'll be also using Streamlit. Streamlit is very easy. If you're using Streamlit, you don't need to write any kinds of HTML and CSS code. So guys, yes, as of now, these are the requirements are needed. If I need it later on, I'll tell you. Okay, now let me show you the project diagram. Okay, the project, let's say, structure. That means the high level architecture. So here, first of all, user will, let me just draw it here. First of all, user will upload one PDF documents. Okay, let's say this is the PDF documents. So what I have to do, I have to extract the data. Extract docs. So why I have written docs? Because I think you already know, if I am using LangChain and if I'm, let's say, extracting any kinds of data from any kinds of PDF or any kinds of, let's say, file format, it would be considered as a documents. I think I already covered multiple times, like LangChain data loader. Even I also showed you inside vector database session. So guys, vector database session is very much required here, because inside vector database session, I have explained each and everything you need to know to implement any kinds of project. Okay, how to connect the LLM, what is documents, what is chunk overlap, everything I have discussed there. So please go ahead and try to watch that, let's say, session first of all, then you'll be able to understand, okay, what is happening here, because here I'm not going to explain in detail everything. We are implementing the project only, and we're using our previous concept. Okay, this is the idea. So make sure you complete that vector database series first of all. Fine. So we'll be extracting the documents from the PDF. Then we have to create a chunks. And what is chunks? I think I already told you why chunking is required, because LLM is having one kinds of input limit. Okay, but, so that's why actually we have to create a chunks. Okay, chunks. Then what we'll be doing, we'll be using one embedding model. What is embedding model? I think you already know. I already explained inside my vector database session. Embedding model will help you to generate the vector embedding. Okay, because I have to convert these chunks to the vector embedding. So this will give me something called vector embedding. Okay, vector embedding. Okay, embedding. And with this vector embedding, we'll be creating one semantic search. I already explained what is semantic search. Semantic search, because I think you know the power of vector DB. It will give you one semantic search kinds of functionality. Now what I have to do, I have to store this vector to a vector database. Vector database, because if I want to perform the semantic search operation, I have to use the vector database. Okay, I think you already know. Now guys, you can see my knowledge base has been created. So this is called actually knowledge base right now. Okay, knowledge base, because it is having the entire information about my data. Now I'll be connecting my large language model here. So let's say this is my large language model. LLM, that means that GPT 3.5. Okay, so this large language model I'll be connecting here with my vector database. Okay, and here I'll set a prompt. I'll just set a prompt here. So inside this prompt, actually I'll be writing what kinds of, let's say, task it has to perform. So here I'll be writing, you are a expert interview question creator. So what you have to do, whatever, let's say, data user will give you, you have to create a interview questions. Okay, or let's say 10 questions, 20 questions, you have to create it. Okay, this is the idea. So this kinds of prompt actually I'll pass to the large language model. So I think you already know prompt is everything if I'm using any kinds of LLM, right? So with the help of prompt we can achieve our task. This is the main idea. So this LLM will go to the vector database that time, and because vector database is having all the information about the PDF, and it will create, okay, it will create what? It will create you interview questions. So it will return interview questions. Interview questions. Okay, fine. Now what I told you, I'm not going to take only the interview question. I will also going to take the interview question answer as well from the large language model. So again, what I will do, whatever questions actually I'm getting, again I'll pass. Okay, again I'll pass to my large language model. Again I'll pass to my large language model, and I will tell my large language model also provide the answer, the questions you have generated. So it will give me the answer at that time. So it will give me questions answer, okay, as well. So this is going to be my complete project architecture. Okay, so based on this architecture, we'll be developing the entire projects. Fine. So first of all, let's do everything in my Jupyter notebook. Then once Jupyter notebook is working fine, then I'll show you the let's say modular coding implementation as well. So for this guys, what I will do, I will open up my local folder, and here I already created one folder here, empty folder. Inside that, I'm going to open up my terminal. Okay. So in case if you're using Anaconda, Git Bash, whatever terminal you are using, you can open it up. Now here I'm also going to open up my Visual Code Studio. So let me open up my Visual Code Studio. Now here the first thing what I have to do, I have to create one virtual environment. I think I already told you. You just need to create a virtual environment every time whenever you are creating different projects. So to create the virtual environment, you have to execute some of the commands. So let me share the command with you as well. So here I'm going to create a file called readme.md. So this is the markdown file. Inside that I can mention all the command, and this file will help you to render actually these kinds of masses in the GitHub. So let's say whenever you will be uploading this code to the GitHub, that time you will see that in the GitHub description, that means your project description, all the details has been written. Okay, let me show you one example. So guys, this is my GitHub profile. You can follow me here also, because here I have created lots of repository that might help you a lot. So let me show you my repository guys, one of the project actually I implemented previously. So let's say this project, okay, MLOps production ready machine learning project. So this is the project actually I created. Now if you open this project and if you go to the readme section, you will see that the complete details about my project. Okay, see the complete details about my projects, like how we can set up, what is the workflow, what are the command you have to execute. Okay, everything I have set here. So how it is rendering, it is rendering because of this readme file. You can see a readme.md file. Okay, so that's why we are getting this readme file here, because whatever things you will be writing here, it will render in the GitHub later on. Fine, this is the idea. So here some of the common command you have to execute every time. Let me show you all the command. So see guys, these are the command you have to execute. First of all, you have to create the environment. After that, you have to activate it. After that, you have to install the requirements. To install the requirements, you have to execute this command. Okay, pip install -r requirement.txt. So let's create a file here. I'll name it as requirement.txt. I'll copy and let me create the file as well. Okay, now first of all, create the environment. So copy this command and open up your terminal and execute it here. Okay, execute it here. For me, I already created the environment. What I'll do, I'll just try to activate it, but for you, you just need to create the environment. So for me, let me activate. So this is the environment I created already. Interview, you can see. Fine. Now inside interview, I have to install some of the required package. The package actually I need, I think I showed you the Langchain, OpenAI, then vector database, fast API. Okay, everything I have to install here. So I already listed down all the required package you need. So these are the package guys you need. Okay, you need to install. So you can see Langchain community, Langchain code. So these are the actually dependency package if you want to use Langchain. So you have to install it. And again, we are doing local setup guys. That's why some additional package you can see. Otherwise, what will happen? Actually, you might get installation issue. That's why I've added everything. Now, OpenAI PyPDF because user will upload PDF documents here. As of now, we are considering PDF documents. Fine. And Token is the dependency of OpenAI. Then you can see AI files, fast API, UVCon. So these are the dependency of fast API. I'll tell you whenever we'll be using these at the package, that time I'll explain. Okay, as of now, just consider these are the packages actually I need to implement the entire projects. Okay, now you can see we'll be using FIAS, and to install the FIAS, you have to execute this command fire CPU, then python.env because I have to manage my secret credential. Okay, now let me save everything and you have to install it. To install it, this is the command guys I already shared. So copy the command and let's execute it here. For me, I already installed all the package. That's why it's telling requirement is already satisfied. But for you, it will take some time. Okay, now let me clear. All right, now first thing, I'm going to create a folder here called research. Inside research, I'm going to create a notebook. I'm going to as experiment. I'm going to name it as experiment.ipynb because this is the Jupyter notebook file I want to create. Okay, that's why it's ipynb file. Now let me select the kernel. So the environment I created, this in interview. Okay, I'll select it up. Now here, first of all, let's import some library. I need the operating system. Then I also need .env. So from .env import load env. Now let me execute. See, it's working fine. So I think remember I have to create a .env file here. Inside that I have to mention my OpenAI API key. So let me do it. So guys, as you can see, I have created this .env file. Inside that I mentioned my OpenAI API key. Okay, so for you, you have to do the same thing. Now let's load this OpenAI API key. So to load it, I'll call this load env. After that, simply I'll call the key OpenAI API key. And I'm going to use os.getEnv. Inside that, I'm going to pass my key. Okay, so this will give you OpenAI API key. Let me show you. See, okay, it is printing the OpenAI API keys. Now let me comment as of now. I don't need to print it. Fine. And now what I have to do, I have to set this OpenAI API key as an environment variable. So for this, you have to execute this line of code. So it will set this OpenAI API key as an environment variable so that OpenAI package will load, okay, from the environment itself. I think I already explained previously this part, okay, how to do it and all. Now the first thing what I have to do guys, I have to load the data, but I don't have any data here. So let me show you some of the PDF actually I'm having. So guys, as you can see in the data folder, I'm having actually two PDF. One is like HGD PDF, one is like stats PDF. Let me show you. Let me open the PDF and let me show you. So if I go to the data folder, so this is the PDF guys I downloaded from the internet. So the PDF name is Sustainable Development Goals. Okay. So about this topic, actually, they have written this PDF. You can see what is sustainable, let's say, development and all. They have written this particular, let's say, PDF. So this is one PDF actually will be using to generate the interview questions. Let's say you want to generate interview question based on this topic. Okay, so you can use this PDF. Not only this PDF, guys, you can use any kinds of PDF, whether it's a Python book, any kinds of physics, chemistry, English, okay, anything you can use here. It's up to you. So this is the PDF, guys, actually I'm having. Now the next PDF, let me show you. So this is the statistics PDF. So this is the topic of importance and the use of correlation in statistics. And again, you can see correlation topic has been written. So we'll be also generating some interview questions based on the statistics. Okay, that means the correlation. So these two PDF actually I just downloaded from the internet. Okay, now let's load the data here. So I'm going to open up my notebook. So to load the data, you have to, I think remember, you have to import one, let's say, function from the Langchain. So let's import it from Langchain dot documents loader. Okay, documents loader, import import PyPDF PyPDF loader. I think, yeah, this one, PyPDF loader, because it's a PDF document, right? Now let me import it. Now one thing I want to show you, so let's say if I show you my project working directory right now, so let's say pwd, this is the command to check my project working directory. Now you can see that I'm inside my research folder. Okay, you can see I'm inside my research folder. So because this experiment.ipynb is available inside my research folder, but where is my data located? Data located outside of the research folder, yes or no? Because outside of the research folder data is available. Okay, now if I want to go back, to my root project directory, that means Langchain project, what I have to do, I have to execute one command. This command is cd dot dot. Okay, cd dot dot is the command. So this will actually go back one folder back. Let me show you. So now see if I execute the command. Now if I again check the project working directory, now you can see that I'm inside my root directory, that means this directory. Okay, Langchain project. Now I can easily access my data right now. Okay, this is the idea. So make sure you always check the path, project working directory. Okay, if you're working with, let's say, Jupyter notebook in a specific folder. Okay, this is the requirement. Now let me define the file path. File underscore path is equal to, so my file is present inside my data folder. Okay, data. And let's say as of now I want to load this hgd.pdf. So it should be DG, okay, sustainable development goal. This PDF I want to load, PDF, okay. And to load it, I'll be using PyPDF loader. Inside that, I'm going to pass my file path, okay, and it will give you loader object. Now I'm going to load the data. So I'll just write data is equal to loader dot load. That's it. Now see, if I execute, it should load the data. Now if I show you the data, see, so the complete documents, so guys, you can see it has extracted all the data from the PDF itself, and it is having around 24 pages. You can see it has started from 0 till 23. That means 24 pages actually it is having, this PDF. If I open this PDF, you'll see that 24 pages it is having, and all the page content it has extracted. And some of the places you can see page content is equal to empty, because in this page actually there is no content, that's why it's empty. And whatever actually documents I'm having, it has extracted, okay, one by one everything. Now if I want to show you the length, you can see 24 pages are available, okay, in the PDF. Now what I have to do, see, it's a separate page content now I'm having. Now I want to, let's say, store all the data in just one variable. So for this, what I will do, I'll just take a variable here. So let's say variable name is question underscore gen. You can give any variable name, it's up to you. It should be initially empty string. Now I'll just write a for loop. So for page in, let's say, data, let's say the complete data I'm having. So it will give me all the page one by one, and I just need to extract the content. So question gen plus and equal. I'll be just adding, okay, in this variable, okay, this is the idea. I'll just write page dot page underscore content. Okay, so it will give me all the content one by one, and it will save inside this question gen variable. Now let me show you. Now if I print my question gen, now see, all the data I have extracted, okay. See, now it is in one place only. This is the idea. Now see, this part actually I have completed. That means whatever PDF I uploaded, I extracted the entire documents, okay. Now what I have to do, I have to do the chunking operation. That means I have to create a chunks for my large language model, because if I want to, let's say, generate the embeddings, before that I have to do the chunking operation. I already explained this part, I think you remember. So to perform the chunking, we'll be using one package. So it is available inside Langchain. So for Langchain.TextSplitter, so we'll be using one text splitter here called token text splitter, okay. So previously I think we used something called character text splitter, then recursive text splitter. I think you remember we use character, okay, character text splitter, okay, splitter. So with the help of that, we can perform the chunking operation, I think you remember. Then we also have something called recursive okay, text splitter. So again, this is another method to perform the chunking operation. And now we'll be using something called token text splitter. Now what is the difference between token text splitter and character and recursive? See, let's say this is my entire documents. So I think you remember we used to perform something called chunk size, okay, chunk size. Let's say 500, and there is another parameter called chunk underscore overlap. Let's say it's 100, okay. Now how it will create the chunks, I think you remember. First of all, it will start from the first and it will count 500 words. Let's say 500 words ends here. So this is our first chunks, okay. And to start the second chunk, first of all, it will apply the chunk overlap. Let's say 100 word back actually it will go. So it will count 100 word. Let's say this is the 100 word start from here. So it will start the second chunks from here. And again, it will count till 500 word. Let's say 500 word ends here, okay. So this is my second chunk, okay. So that's actually it will perform the chunking operation. Now you can see there is a chunk overlap you got. So this is called actually overlap, okay. This is called overlap. And with this overlap, actually my model will understand after this first chunks, this chunks is coming, because you can see it is getting overlap now. This is the actually manual approach actually we can consider. This is the manual approach we can consider to get the context of my first chunks and second chunks, okay, and so on, like whatever chunks actually we are defining here. But this is actually what we do in the character text splitter or recursive text splitter. But what about token text splitter? See, token text splitter, what it will do, instead of using, okay, instead of using actually this manual approach, it will use one large language model. In case actually we'll be using something called GPT 3.5. Okay, so this GPT 3.5 will decide, okay, how to create the chunk, how to perform the overlapping, and it will automatically remember, let's say after this first chunks, this second chunks is coming, after second chunks this third chunks is coming, after third chunks this fourth chunks is coming. Okay, your large language model will try to remember this part. Okay, and this is like more powerful method than your previous one, whatever, let's say, method you used previously, because now LLM is like remembering everything, the context. Okay, that's the idea. So let's try to export this this token text splitter. So for this I'm going to open up my notebook. So I already imported. Now let me execute. Now see, this is the syntax to use the token text splitter. So I think you remember previously we didn't use any kinds of model name whenever we used to perform the, let's say, chunking operation. Now you can see I'm using the model name. I'm using GPT 3.5 Turbo. That means my model will try to decide, okay, how to remember the context. Now you can see this is the chunk size. Chunk size I'm expecting 10,000. Okay, 10,000 actually word would be considered as one chunks, and chunks overlap should be 200. Okay, as of now, let's say this is the things I'm just showing you, just to show you, okay, how it will work. It's just an experiment. Okay, I'm just showing you how it will try to create the chunk. Now let's define the splitter. Okay, this is my splitter. Now inside that I'm going to pass my entire documents. So you can see the entire questions and documents actually I'm passing to my splitter. Okay, splitter objects. You can see split text. Now it will give me chunk questions, and that means the chunking. Okay, it will give you the chunking result. Let me show you. So here is the chunk I got. See, this is the chunk I got. Now how many chunk it has written? For this you can use length function. You can check. See, it has only given me one chunk. Because why? The PDF, you can see this PDF is DG. So if you count all the words, it won't be actually 10,000 words. Okay, it won't be 10,000 words. It is less than 10,000 words. That's why here I've given chunk size is equal to 10,000. It is only considering one chunk the entire documents, because I told you if you count the all the, let's say, word, okay, in this let's say PDF, it won't be 10,000. Okay, because it's a like huge size I have given here, just to show you, okay, how chunking will happen. Now let's perform our actual chunking. For this, what I have to do, I have to first of all convert this actually data to the document format, because you can see now it's a list format. Okay, if I show you the type, okay, if I show you the type of this one chunk question, it's a list. Inside that, if I just extract the first element, it would be a string. See, it's a string, but I have to convert to the document representation. So for this, what I will do, I'll import one class from Langchain called docstore documents import documents. Okay, with the help of documents we can easily convert any kinds of string to document representation. Okay, now let me show you. See, now whatever, let's say, data you got, that means your this one chunk question gen. So I'm applying on for loop. That means it will give me all the, let's say, data one by one, and I'm converting to the documents, you can see. Okay, and I'm storing in this particular variable. Now if I execute, now see, I got the documents and it is format of documents right now. Okay, now if I show you the type of document question gen, it should be a Langchain code document base documents. Okay, it's a now document format, because if I want to apply the splitter, so first of all you have to convert everything to a document. This is the recommended way. Okay, if you're also giving the, let's say, string directly, it's completely fine, but this is the recommended way. First of all, convert everything to the document format, then try to use the splitter, that means the chunking operation. Now I'll do the chunking again. See, again token text splitter. Again, I'm using GPT 3.5 Turbo model. Now I've given the chunk size is equal to 1000. That means 1000 word I want to consider as one chunks, and chunks overlap is equal to 100. Okay, now let me execute. Now let me give my documents. Now you can see document question gen. Okay, I'm passing it to my splitter. Okay, splitter object right now. Now it will give me the chunk. Now let me show you. Now see, I'll get multiple chunk here. So I got here 4 chunks. Okay, 4 chunks actually I got from the entire PDF. Now if I show you the length, see, 4 chunks I got. Fine, I think it is clear now. So guys, as you can see, we successfully created the chunks. Now the next thing what I have to do, first of all I will generate the questions.
like whatever, let's say, chunk I have created, I will pass to my large language model and I will generate the questions. Okay, interview questions based on the prompt actually I'll be providing. I think you remember, we'll be passing one prompt to the large language model. Okay, so with the help of this prompt, actually, I'll tell my large language model, I need a interview questions. Okay, let's say the documents I have given, based on that, it should provide me some interview questions. That's what actually I need to perform. So for this, I don't need to convert these documents to the embedding representation, because as of now, we are only passing the, let's say, documents to my large language model. Large language model will give me the questions, but later on, whenever, let's say, I'll be doing the answer generation, okay, the complete answer generation, that time actually I need to pass the entire documents. Okay, and it will create the vector embeddings and it will store to the vector database. Okay, and vector database, I'll connect my large language model, and large language model will refer this entire information to give me the answer as well. Okay, this is the idea. So let's define my large language model right now. So here I already told you I'm going to use something called OpenAI large language model, that means GPT 3.5. okay, this model. And to use it, I can use this class actually, chat OpenAI. You can also directly import OpenAI, it is completely fine, but we can also import like that. Okay, both way you can import. And if I am importing like that, so here I can also give my model name. That means which specific model I want to use, whether I want to use, let's say, GPT-4 model, 3.5 model, you can use. So let me show you. So this is the code snippet. So chat OpenAI, inside that you can give the model name. Let's say I want to use GPT 3.5 turbo model, and this is the temperature parameter. You can also give max length parameter and so on. So temperature parameter is a creativity parameter. I already explained. Okay, what is the temperature parameter? Now let me define my LLM. Now here I already created one prompt, guys, prompt template. Let me show you. So this is the prompt I have created, guys. You can see you are an expert at creating question based on the coding material and documentation. See, whenever I designed this prompt, actually I was like generating coding related questions, and now I'm using any other documents. You can see that means the this one, sustainable development goal and statistics one. So if you're using statistics one, that time you need to give statistics material. If you're doing sustainable development goal, you have to give sustainable development goal here. That means whatever subject you are referring, you have to give the prompt with respect to that, because it's a changeable prompt, is changeable. Okay, you have to change every time based on your requirement. Now your goal is to prepare a coder for a programmer for their exams and their coding test. You do this by asking the questions about the text below. That means whatever, let's say, data user will provide, that means these chunks. Okay, based on that, it will create interview questions that will prepare for the coder, a programmer for their exam test. Okay, make sure not lose any important information. Okay, this is the prompt actually I have created, and I already told you like how we can design a efficient prompt. What is the art of, let's say, design a prompt? I already took on session on the prompt engineering. That session you can refer. Okay, so that's how always you have to prepare a good prompt. Whenever you are preparing good prompt, that means you will get a good response from the large language model. This is the idea. Now let me define the prompt. Now to use this prompt, I think I already taught you one concept called prompt template. You have to use something called prompt template from the Langchain. So let me show you. So this is the code snippet, prompt template. Okay, so here I'm passing the prompt template I've created, and this is the input variable is text. That means user will give this data. Okay, this is the input variable. I think it is clear. Now let me execute the prompt. Okay, now this is my template right now. We can do another actually very important, let's say, technique here. See, if you're not doing it, it's completely fine, it will work. But I was going through some of the research article, and I got to know people are using something called second layer verification. That means they are doing refined prompt template. So what is refined prompt template? Let me show you. I created one prompt template. See, this is the prompt template I again created. That means whatever questions actually your model will generate from the first prompt, you have to give those questions to the second prompt. That means it will refine that particular question. Let's say if there are some issue with the question, if let's say this question is irrelevant based on the topic you are asking, again this refine prompt template will try to refine, and again it will give you some new questions, okay, on top of it. So here you can see I've written the same prompt again, but one more additional information I have added. We have received some practical questions to certain context. That means it will give me some question. Okay, this question actually I have to give to my second prompt, and second prompt will try to check. We have the option to refine the existing questions or add new one only if necessary with some more context below. That means if some issue is there, if let's say it is irrelevant, that time what it will do, it will try to rectify that question. Okay, this is the idea. Give the new context, refine original questions in English. If context is not helpful, please provide the original questions. This is the idea. So this will actually refine prompt template. You are refining the questions here. That is the idea only. And this is like very powerful method, guys. If you are using, you will see that your result would be pretty good. If you're not using it, it's completely fine. No need to worry. But I'm showing you because see, we are creating it an advanced application, and in advanced application, we have to take care. These are the part. Okay, this is super important. Let's also define this refine prompt template. Again, I'm going to use prompt template. Inside that, I'm going to pass the input variable. Now input variable is two. One is this existing answer. The existing answer I will get, and the text. That means again you have to give the entire text. That means the chunks. Okay. So these two input now you have to give. You can see text and existing answer, and it will give me the refine prompt template. Fine. Now I'll generate the questions. For this, I need to integrate my large language model as well as the prompt template. For this, I'm going to use one function from Langchain called load summarize chain. Okay, previously I think I showed you we can use chain. Okay, only chain we can use. Now there is another chain actually called load summarize chain, because inside Langchain you are getting different chains. Okay, we are using this particular chain, actually load summarize chain. Now we'll be creating my entire chain. See, this is the entire chain. First of all, you have to give the large language model. Okay, the LLM we have defined GPT 3.5. Then chain type is equal to refine, because we have prepared one refine prompt template. Okay, that's why it's a refine. Verbose true, that means it will show you the execution, all the, let's say, logs. Then here I'm giving the question prompt. First of all, the prompt I have defined at the very first. Okay, this is the question prompt. Okay, because it's a chain, it will execute after one after another. Okay, first of all it will execute, and whatever question actually I'll be getting, I'll pass to the refine prompt template. Okay, you can see refine prompt template. Okay, now this is going to be my chain right now. And now simply I'm going to pass the document question. That means this one I have to pass, this one. That means the entire document. Okay, this document I have to pass right now to my large language model, and it will give me the questions. Okay, it will give me the questions, and these questions I'm printing. Let me show you. See, it is generating and it is giving all the information because you have defined verbose is equal to true. Now see, these are the questions I got. I got 10 questions. Now if you want to get 100 questions, you can define here. You can define inside the prompt. I need 100 questions. Okay, you have to generate 100 questions. It will generate 100 questions. By default, it's generating 10 questions. Now if I want to show you, I will open in a text editor. See all the 10 questions I got here. But apart from that, I'm getting some more additional information. I don't need them. I only need the questions. You can see 1 to 10 questions it is giving me. What is the main goal of the sustainable development goals method? What are the some key achievements in the, see, that means if you read these questions, it's pretty good. Nah, as a human, if I tell you just prepare the question for me, I think you will be thinking in that way. Okay, this is the idea. That means my answer is pretty good, guys. And why I got the pretty good answer? Because I used the refined prompt template. Okay, so this is another powerful concept you can use. Okay, so now we'll be creating the next part. That means we'll be using the embedding model. We'll be generating the vector embedding, and we'll be storing to the vector database. Okay, because I also need to generate the answer right now. Fine. So this is what I have to perform. So let's do it. So for this, first of all, I have to define one embedding model. So here I'll be using OpenAI embedding model. So for this, you can import from the Langchain embeddings OpenAI. I need OpenAI embedding model. Okay, so let me initialize. So here I'm going to use OpenAI embedding model. So if you go to the OpenAI website and if you go to the model section, you'll see that OpenAI also provides lots of embedding model. Okay, so you can use any of them. Now I also need to initialize my vector database. So here I'm going to use FIES vector database. I already told you. So it is available inside Langchain vector store FIES. You can also use ChromaDB, Pinecone, Weaviate. It's up to you. But I'm going to use the FIES because I need to show you the FIES as well. Okay, and FIES is very like fast. Than your ChromaDB. Okay, you'll see that it's like very fast, quite fast. Now let's initialize my vector store. See, that's how you have to initialize the vector store. FIES from documents, and you have to give the documents here, like which document you want to create the embedding. I think remember we created the chunks. These chunks, I think remember. Document answer gen. These chunks I have to pass, and I have to create the embedding. Okay, and I have to give the embedding model. This is the embedding model I'm passing. So this will give you the vector store, and it will save locally, guys. Okay, it will save locally. You won't be able to see that. Okay, it will save in memory actually. And if you want to see that, you can store in the cloud-based. You can use the cloud vector DB that time in the cloud. You can save. I think I showed you the Pinecone. There you can see the visualization of your vector. Okay, it's possible. Now let me again initialize my large language model. You can see again I'm using GPT 3.5 Turbo large language model to generate my answer, because you can see I told you na. The question I'm getting, I'll again pass to my large language model. Large language model will give me the answer. Okay, that's why I'm initializing my LLM again. Now previously I got some questions, I think remember. So this is the questions I got. Okay, these are the questions I got. If I show you beautifully, So what I can do, I can split with the help of /n. So it will give me line by line everything. Now this is the question list. See, so this 10 question I got. Now I have to generate the answer of this 10 question, okay, with the help of large language model. Now for this, let's create a retrieval QA, okay, question answer, let's say chain, because inside chain we are having different chains. I think I told you. Now I'm using retrieval QA chain. This chain I already used in my vectoridb. I think you remember. Let's create it. Now let's initialize my QA chain. So here you have to give the large language model first of all. Now you have to give the chain type is equal to stub because it's a QA chain, okay. Now you have to give the retriever object. That means your vector store. That means you are connecting with your large language model right now. See, LLM, you are connecting with the vector store. Okay, for this you have to write this code, vector store as retriever. That's it. Now this is going to give you one chain. Now you can give the, let's say, question and you can get the answer. For this I written a for loop here. See what I'm doing, whatever question list actually I'm having, I'm looping through it. That means I'm taking all the question one by one. Okay, you can see. Then I'm printing it. Then I'm generating the answer. You can see I'm calling this chain run question. That means I'm giving the question, it will give me the answer. This answer actually I'm also printing. After that, I'm opening a txt file. Inside that, I'm just saving it. Okay, inside that I'm just saving it. That's it. As of now, inside a txt file I'm saving it. Going forward, inside a CSV file I have to save it. Okay, this is the idea. Now let me execute. See, first of all, this is the first question. It is generating the answer. See, this is the answer. Okay, second question, it is generating the answer. Third question, answer. Fourth question, answer. So that's how it will generate for all the questions. Let me show you. See, beautifully it is generating. So we have created one amazing application, guys. Now we have to convert it the modular coding. That's the idea. Now see all the answer I got. And if you read the answer, guys, if you open your text editor and if you read the answer, it's pretty good. It's pretty good. If you see that question and answer, it's pretty good. Now you can use as it is. As it is for any kinds of exam, any kinds of interview, you can prepare. It's amazing, right? Okay, so this is the entire actually, let's say, notebook experiment of our project. Now let's try to convert everything in a modular coding. Modular coding is I just need to write everything in a function. That is the idea only. Okay, I'll refer the same notebook only. I'll copy paste the same code, but I'll write everything in a function. Okay, so there is nothing new I'll be doing. So let's start the modular coding. So guys, now let's start the modular coding. But before that, let me show you this answer.txt. Now see, inside answer.txt, it has saved everything, all the question and answer. But again, it's not readable. So next time what I will do, I'll save everything in a CSV file. In one column, I will add the question. In another column, I'll add the answer. Okay, that would be more readable. So what I'll do, guys, so now let me close everything. So left hand side, I'm going to create a folder and I'm going to name it src. Okay, src, because this is going to be my source folder. Inside that, I'm going to write some helper related function. That means if you open up any kinds of, let's say, real-time implementation of any kinds of package or any kinds of project inside Python. Let's say if I open this one, Keras, GitHub, you will see that they have also created this kinds of folder structure. See, this is the Keras. Now Keras is also using this. See, it is having one root folder Keras. Inside that, they are also having the source src, and inside src they have created all the, let's say, utility related functionality. That means whatever functionality they need, let's say activation function, application, backend, callbacks, they're writing everything here and they're integrating in the endpoint. Okay, it is also having some endpoint. See, API gen, this is the endpoint, and they're importing it here. If you open it, any kinds of endpoint, they're importing it here. Okay, this is called actually modular approach. That means instead of writing everything in just one file, we have to create a separate file, separate function, and whenever I need it, I'll just call it. Okay, from that particular, let's say, a helper function. This is the idea. So inside src, I'm going to create a file called __init __.py. Okay, this is the constructor file because this folder would be considered as my local package right now. See, this is the modular concept, guys. This modular concept I already explained in my Python session. Okay, so I think you know. So guys, this is our YouTube channel. So here, if you go to the playlist section, I already created complete Python course. So here I already explained about modular coding, everything. What is this constructor file? What is modular coding? How we can write any function in any other file, how we can import it in the endpoint, everything I have explained. Just try to go ahead and watch that one because modular concept is required here. Okay, I'm expecting you are already familiar with this kinds of Python concept. Fine. So you can also see the master OP actually playlist. So there also I have covered lots of advanced topic related Python. So that's why I'm creating this constructor file because this folder would be considered as my local package right now. Okay, and inside that I'm going to create a a file called helper.py, and I'm going to create another file called prompt.py. Okay, prompt.py. So inside prompt.py, I'm going to mention my prompt. So let me show you. So the prompt actually I showed you in my Jupyter notebook. So here I'm going to just define. See, this is my prompt template, first prompt template, and this is my define prompt template. Nothing new, guys. I'm just copy pasting from my notebook only. See, the same prompt I just copy pasted, because prompt is a changeable. Okay, it's a changeable, it's a static one, people can change anytime. So that's why I've written inside prompt let's say file. So user will open the prompt file and there actually they will change, so that they don't need to open the actual code implementation, and inside that they don't need to change. Okay, I don't need to hard code these are the value. That's why I kept this separate entity. I hope it is clear now. Now let me close it. Now inside helper.py, see, whatever code I have written so far, that means I loaded my documents, I performed the chunking operation, then I created the questions. Okay, these are the thing I'll be writing inside a function only. So inside helper, I created two function. First of all, you have to import all the required package you need. I think you remember these are the packages actually I need. I loaded in my notebook. Then I need to load my I need to load my OpenAI API key, and I have to set as environment variable. I think you know, got it right. Now the first function I have written called file processing. Same thing, guys. If I show you the same thing I'm performing here. First of all, I'm loading my documents. I'm adding all the, let's say, content inside one variable. I was performing this one. Chunking operation. First of all, I was doing with the help of 1000 token. Then next time I was doing with the help of, first of all, I was doing the 10,000. Okay, 10,000 chunk. That means one chunk I want to consider as 10,000. Then I was doing for the 1000. That means the same experiment I did here. Remember, same experiment. See, same experiment. I just written inside a function only. That's it. That is the difference only. This is called actually modular approach. You can also create a Python class, but as of now, it's a very, let's say, a small implementation. That's why Python class is not required. But if you see the actually very big implementation, any ML project or deep learning project, you will see that there I've written like lots of class. Let me show you. So inside US Visa, if I open the components, that let's say data ingestion, you can see I've written a class that time. Okay, so class is required because you can see lots of function I have to handle, and whenever you are having lots of function, lots of method, that time you can write a class. But here I don't have actually lots of method. I only have 1 to 2 method. Okay, that's why I've just written directly a function, not a class. Okay, this is the idea. So that's how you have to design your own project, whether your project size is very huge or not. If it is huge, try to maintain the class, otherwise try to maintain the function. This is the difference only. So if you see any kinds of GenAI project, so most of the time actually we create, let's say, inference on top of large language model, we create a RAG application on top of large language model. Okay, that's why the code implementation is not big that much of. But whenever actually I'm creating any ML project, DL project, there actually we are training our custom model. That time actually lots of method we have to handle, very big code base we have to handle. Okay, that's how we need class concept. This is the idea. Now you can see, guys, I will get my object. Okay, object related my chunking. You can see it will give me document question gen. That means after performing the chunking, and document answer gen. Okay, both actually it will provide. So question gen is nothing but you can see I'm converting to the documents this question, whatever questions actually I was getting. So this is the document question gens. That means after converting to the documents, whatever documents I'm getting, this is my document question gen. And after doing the chunking, this is my document answer gen. So this question generation and this document I need for the answer generation. Okay, the same thing I perform in my notebook. I think remember. See, first of all, I was using document question gen just to generate the question. Okay, then I was using document answer gen just to generate my answer. Okay, I hope it is clear. So this function I have created, guys. Now the next function I have created my LLM pipeline. That means I will be using my large language model. I'll be creating the vector embeddings. Okay, so everything will happen inside this function right now. LLM pipeline. First of all, I'm calling the file processing. That means this function, inside that whatever file user is giving, this file would be processed and it will give me document question gen and document answer gen. I'm creating my large language model, creating the prompt, both prompt actually. That means my prompt question as well as the refined prompt. Okay, both I'm creating. Then I'm first of all creating load summarization. I think remember load summarization I was creating. Okay, this one. So it will give me the question. It will give you the question, and I was creating the vector embedding after that. Vector embedding. Then I was creating the vector index. You can see vector index. Then I was creating the retrieval keyword that time. Okay, it will generate you the answer. That means question answer. That means here you will get answer question generation chain and filtered question list. Okay, both actually will get. So these two function I prepared here. Now let me save. Now let me create the endpoint. So here what I will do, I'll create a file. I'll name it as app.py. Okay. Now this is going to be my endpoint. So inside that I'm going to call this function, actually this LLM pipeline, because inside LLM pipeline I'm calling my file preprocessing. That's why I don't need to call separately. So let me open it up. But before that, let me initialize my fast API related code. So if you go to the fast API documentation, guys, you will see this is the starter code. That means this is the demo code they will also give you. So these are the library you have to import one by one. Okay, then you have to initialize the fast API. So how to initialize the fast API, guys? So that's how you can initialize the fast API. Okay, see, this is the code to initialize the fast API. Now here you have to create two folders, static and templates. Inside that you have to create the index.html file. So inside template folder, you have to create a index.html file, because index.html file would be your home page. Okay, that means the user interface. So you need some HTML code. Let me show you. I already created. So guys, as you can see, I already created one template folder. Inside that I created a HTML file. Okay, now see, inside that I have written already HTML code. Okay, that means my front end part of my application. And how I created, again, I referred that Bootstrap website. I think you remember. I also used the Bootstrap website. If you don't know about HTML code, it's completely fine. You can skip this part. You can use, let's say, any other framework, let's say Streamlit on. And see, this HTML creation would be done by the front-end developer. As of now, just to beautify this project, I created the HTML, okay, from my end. That's the idea. And there is another folder I created called static. Inside in static, I created two folders called docs and output. See, whatever documents user will upload, that PDF, it will save inside documents folder. And whatever output you will get from the, let's say, application, that means the question and answer in a CSV format, because you can see I've imported the CSV, it will save inside output folder. And from output folder, actually, I will get that particular, let's say, CSV output. Okay. And inside documents, it will store the PDF. That's the idea. Now, this is the fast API code, guys. Fast API will handle each and everything. Now, I also need to import this one. That means my LLM pipeline. Let's import. So it is available inside, I'll call it from, let's say, src dot, let's say, helper import LLM pipeline. So it is inside helper. I need to import LLM pipeline, because inside helper I have this LLM pipeline. Okay. Now see, if I am importing like that from src helper import LLM pipeline, that means src is now considering my local package. And if I want to use src as my local package, what I have to do, I have to create one file called setup.py. Okay, setup.py. So this is the modular coding concept, guys. Again, inside setup.py, you have to write some setup related code. Let me show you. So this is the code, guys. Setup tool. First of all, give the project name, version, author name, author email, package, and install requires. That means this find package will try to find, okay, wherever this constructor file is available, this folder would be considered as my local package. Now you can see constructor file is only present inside src. That means src would be considered as my local package. Now see, if I show you pip list inside my environment, see, src is not mentioned. Src is not a package. Okay, see, src is not a package. But whenever I will install it, whenever I will install this setup, you will see that this src would be considered as my local package. That means there would be a package name called Generative AI project. You can give any name. I've given Generative AI project. Now let me save. And to install it, in the requirements, you have to add one more line called -e space dot. Okay. So this -e space dot will look for the setup.py and it will install this package. Okay, let me show you. Now if I again run, let's say pip install -r requirement.txt. See, this would be installed as my local package right now. Done. Okay, now see, some egg info file would be created. Okay, whenever this egg info file is created, that means this setup is successful. Now if I again open up my environment, let's say pip list. Now see, there is a package it has created, Generative AI project. Okay, now see, it is my local package right now. That means this src would be considered as my local package. Now I won't be getting any kinds of error right now if I'm importing like that. Okay, so this is called actually modular approach. I think you got it. So here, first of all, user will upload one PDF. For this, I have written a function with the help of fast API. See, this is the function. So there is a route called upload. User will upload one, let's say, file, and this file would be saved inside my documents, inside statics documents. Okay, it will save. Now there is another function I will create called get CSV. That means the complete results. Okay, I want to save as a CSV file. So this function will help me to do that. That means the file actually I'll be receiving here. This file I'll give where in the LLM pipeline. And LLM pipeline, what it will do, it will pre-process. It will create the, let's say, prompt and everything. Then it will give me the that means chain, entire chain. Okay, and that chain actually I will utilize. Here you can see. So you can see I'm getting the entire chain, and whatever question list actually I'm having, okay, question list, I'll pass the question inside my chain and it will give me all the answer. And this answer actually I'll save inside my CSV file. You can see write row. Okay, CSV writer write row, and with for this actually I'm using CSV package. You can see CSV package. Very simple code, guys. Only have written inside a function only. You just need to go through this code. You will able to understand. Okay. Then I need another function, guys, called chat. So this particular function, what it will do, it will load the output file. That means the CSV file. Okay, and it will show. It will return you. Okay, it will return you. That means you can also see the complete PDF. Okay, in the UI. Let me show you how this application will look like. So now let me execute my first API code. See, this is the first API code. Even you can run app. Oh, this is the local host and this is the port number 8080. Okay, now let me save and now let me execute. So I'll open up my terminal. So python app.py. Now see, it is running. Let me give the allow permission. Now I'll go to my Google Chrome and here I'll search for localhost 8080. See, this is the user interface, guys. Okay, now here you can upload a file. First of all, let's say I'll upload this file inside data. Let's say I will upload this SDG. First of all, this sustainable goal development, and here I'll generate the question and answer. Let's see. It is generating. This is the user interface we created, basic user interface. Now see, it's loading. And how this loading is happening, animation is happening, because I written everything inside HTML code. So guys, you can see I got the output. Now left hand side you can see it has rendered my entire PDF. Okay, the PDF I uploaded, and right hand side it has given me the CSV download. And now see, if I click here, it will download the CSV file. See, QA CSV. Now let's open the CSV. How I can open? Let's open it here. So I'll open it. See, this is the CSV. I don't have Excel right now, guys, in my system. That's why I've opened in a VS Code. You can see this is the question, this side, and that side actually I have the answer. You can open in a Excel viewer. You will see that it's a beautiful format I have just stored. Okay, so that's how actually things are happening. Okay, now I think you got it. Why we have written these are the function. So this function will help you to render your PDF documents, as well as it will give you the download option. Okay, to download this particular PDF. Now let's upload another PDF. Let's say I will upload this statistics one right now. Now let's generate again. So guys, as you can see, I got the results, and this is my PDF I uploaded, and let's download the QSSB as well. See, this is the correlation answer and question I got. Fine. So yes, guys, this is the project actually. I hope you liked it. And this is like very interesting project, guys. If you develop it, you will feel like it's like very interesting. Going forward, we'll be also implementing lots of projects. No need to worry. So in the next video, we'll be implementing another amazing project, very interesting project called Chatbot for any website. That means, let's say I think you saw website chatbot. If you go for any kinds of website nowadays, they're having their chatbot integration with that. Okay. So if you ask, let's say, some question related about the website, about their, let's say, product and service, it will able to give the answer. So that means they're replacing the human behind it. Previously, they used to, let's say, use one human. They used to receive the chat. They used to give the reply. But nowadays, they have added the chatbot there. Chatbot can handle all the answer. If you go to any of the website, you will see that. So we'll be implementing these kinds of application. That means the custom website chatbot. It will only work based on our website data, not any other, let's say, question and all. Fine. This is what actually we'll be implementing, and this is kinds of RAG-based application we'll be creating. Okay, that means we are using our custom data. On top of that, we are adding our, let's say, like a large language model. Large language model will try to refer that data to provide you the answer. Fine. So in this implementation also, I'm going to use LangChain large language model. Even we'll be also using something called vector database. Okay, with the help of that, actually we'll be implementing this entire application. But see, this application would be a little bit advanced, because here we'll be creating something called the RAG based system. Okay, like retrieval augmented generation. This is the basic RAG. So here we'll be using our custom data. So custom data wise, actually we're going to use our website data. That means we'll be giving some website. Okay, website URL. So my LangChain will automatically fetch the information from the website itself, And this data actually I'll give to my large language model. That means my LLM would be connected with this data. And if you're asking something related about this website, okay, it will give you the answer related that. Okay, so this is the application we'll be implementing. So first of all, let me show you the architecture, like how we are going to develop this project. Then I think this part will be clear. So before showing you the architecture diagram, guys, let me show you one thing. So let's say if I want to open any kinds of website, let's say I will open this openai.com. Okay, this one, openai.com. So this is the openai.com website. Now see, if I want to see the let's say XML page of this website, so what I can do, I can give this particular, let's say route here. So slash sitemap sitemap.xml. So if you open any website and if you give slash sitemap.xml, it will show you the entire structure of the website. Let me show you. So guys, here you can see this is the page actually I got. Now see, inside openai.com, okay, inside openai.com, whatever, let's say, content you are having, whatever content, whatever sub pages you are having, all the information is coming here. You can see, if you just see it carefully, so it is having different URL, okay, different URL for the different tab. Let's say research, for research actually it is having one URL. For GPT 4.40 it is having one URL. For safety, company, see company, I think I saw here. So see, this is the company one. Okay, this is the company one, you can see. Okay, company one. So I think I showed you the company. So see, this is the company URL. So that means it is having all the information, all the data, whatever content you can see in this website. Okay, everything is visible now in this XML page. Now what I have to do, I have to use this concept to extract the data. That means I'll be using Langchain data loader. So inside Langchain actually we are having website loader. With the help of that, we can easily load these are the content. So I'll tell you how we can extract the information. So this is the things actually we'll be doing. Now let me show you the architecture diagram, what we are gonna perform here. So let me open up my Blackboard. See here, first of all, I told you we'll be using website URL. Okay, website URL. So from website URL, what we'll do, we'll just get this sitemap, sitemap.xml. Okay, this page. And from this page actually, we'll be getting different sub pages as well. Let's say page 1, then page 2, page 3, okay, and so on. That's a multiple page actually we'll get from here. Now what I have to do, from each and every page I have to extract the documents, that means the data. So it should be docs1, let's say docs2. Then after getting all the documents, we'll be using one embedding model. I think you know why embedding model, because I have to convert all the documents to the embedding representation. Okay, so I'll pass all the data to the embedding model. Okay, and embedding model will try to return embedding, vector embedding. So you will get different vector embedding, let's say 0.2, 0.3, 0.5, and so on. Let's say these are the vector representation as of now, just try to consider. Then with all the embeddings, what I have to do, I have to create one semantic index. Okay, semantic index, I think you know, build semantic index. Okay, build semantic index. Then this semantic index, that means this embedding, I will store where? I will store to the vector database. Let's say this is my vector database. So in this case, actually, I'm going to use FIAS. You can use any other vector DB. Let's say this is vector database. Okay, I'll be using FIAS. You can use anything. You can use, let's say, ChromaDB. You can use Pinecone. I'll tell you how to use Pinecone ChromaDB. Later on, I will also tell you. Now, what will happen? So user will ask question. Okay, user will ask some question about the website. And this vector DB will return some ranked results. Okay, I think you know what is ranked results. Ranked results. Okay, rank results I'll get. But what I have to do, I have to initialize my large language model, because with the help of LLM only, I'll able to get the correct response. So what I will do, I'll pass this rank results to my large language model as well as this query also. Okay, and this LLM will give you the actual response. Okay, actual response. So this is the complete idea. Okay, this is the complete architecture of our application. Okay, and this is called actually RAG. Okay, RAG. That means retrieval augmented generation, because here we are integrating our custom data. Okay, and we're integrating our large language model with that data. That means this is called actually knowledge base. Okay, knowledge base right now. Okay, entire knowledge base. So now let's open up our Colab notebook and try to install everything and let's implement this project. So guys, as you can see, I opened up my Collab notebook. So first thing, just try to change the runtime. So here runtime, just keep it as CPU only because here we'll be using OpenAI model. But if you want to use, let's say, any other open source model, that time you can use GPU, okay, that time. So as of now, let's keep it CPU only. So later on, I will also show you how we can use a new open source large language model. Okay, now let me connect this notebook. So here, first of all, you have to install some package. So you can see I'm installing LangChain, LangChain community, PyPDF, then a sentence transformer, okay, OpenAI, TikTok, and these are the things. So these are my dependency package actually I need. So let me install all of them. So some of the package actually you don't need. I just written additionally because later on this project I will show you how we can implement with the help of open source large language model. Okay, that time actually this sentence transformer is required because if I want to use any, let's say, open source embedding model, that time this is required. So as of now, let's install everything. Then apart from that, I also need to install some more packages. So TikTok and Fire CPU and unstructured. Let's say if I want to load the website now, website data, that time I need this package unstructured because it's unstructured data. And again, I'm going to use Fire's vector database. Okay, that's why Fire CPU I'm installing. So let me install all of them. Then I also need to install NumPy and NLTK. Okay, so let me install. Because these are some dependency packages. If I want to extract the information from the website, so LangChain needs, these are the dependency. Okay, so that is why actually we are installing everything. Now see, after installing this NumPy and LTK, it will tell you restart the session. So let me restart the session. So it will restart the session. Then after that, we'll be importing all the necessary library we need. You can see I'm loading unstructured URL loader from LangChain. So with the help of unstructured URL loader, we'll be loading this data. Okay, here we'll be giving the URL, website URL. It will automatically extract all the information. And we'll be performing the chunking. For this, we are using character text splitter. OpenAI embedding will be using just to convert my data to the embedding representation. We'll be using OpenAI large language model, GPT 3.5 Turbo. That's why we are using OpenAI. Fires, this is the vector-DB, retrieval keyway with source chain. That means it will create the keyway object. That means the chain object. Okay. And Hugging Face embedding as of now, I don't need. I'll just try to remove it. Okay. Later on, I'll tell you how we can use the Hugging Face as well. Now let me import all of the packages. So it's working fine. There is no error. Now let me download this two thing like PUNKT. And you have to download another thing, Average Perceptron Tagger. Okay, so this one you have to download from the NLTK. So let me download. Then after that, I will set my OpenAI API key because here I'm going to use OpenAI large language model. Definitely you need the key. Now I'm going to pass different website URL. So now you can see I have just collected different website URL. Let me open all of them. Let me show you. So these are the website actually I'm going to refer. So this is one blog website, Medium website you can see, and the content about paper review, Llama 2, Open Foundation, fine-tuned chat model. Okay. Now if you just read it, you will see lots of content related Llama 2. Okay. Now there is another website, Databricks I'm using, introducing MPT7B, a new standard for the open source community usable LLM. So this is another large language model. Now you can see the information is written about this large language model. That means we'll be extracting these are the data and we'll be creating one chatbot. It will provide, and that chatbot actually will be able to give the answer related. These are the topic. Okay, the topic actually you have feed. Let's say Llama 2, then MPT7B, then stability.ai. Okay, so this is another website. Then you can see Vicuna. So this is another website. Okay, so these are the information actually I want to see. So I have given all the website link. So here you can pass any kinds of website link. You can pass any kinds of website link. Let's say you have one website, your own website. You can give the website link here. So this will automatically extract your website information and you can create your website chatbot. Okay, on top of it. This is amazing. Now let me initialize the URL. So it supports actually multiple website URL. It's not like that it only supports one URL. No, multiple URL you can give here. Now let me extract the documents with the help of unstructured URL loader. Inside that you have to pass all the URL and it will automatically extract all the information. Let me show you. Now if I print the data, all the information it has extracted from all the websites. See, okay, amazing. Now if I show you the length, you'll see that 4 documents it has written. Why 4 documents? Because I have given 4 website, 1, 2, 3, 4. That means 4 website information I'm having right now, and this is in the document format. Got it? Because I already told you if you are loading anything with the help of LangChain, that should be document format always. So now I think this part is clear. So we have extracted the content successfully. Now what I have to do, I have to create the chunks. Okay, I have to create the chunks, different chunks. You can see these are different chunks. So I think I forget to mention this chunking here. So it should create a chunk. Okay, chunk. Okay, all the chunks. That means it will create all the chunks. These chunks actually I'll give to the embedding model. Okay, now let me create the chunk here. So to create the chunks, actually I'll be using character text splitter. See, these are some repetitive code. Again, I'm using. Previously, I also already taught you what is character text splitter, what is chunk size, what is chunks overlap. Everything I taught you, even in the vector database session. So this is very much important session, guys. Just try to complete that session first. So you can see character text splitter, separator is equal to /n, because you can see /n is there. Okay, sometimes. So slash would be the separator. So here /n would be the separator. It will separate by /n. Now chunk size 1000, chunks overlap 200. Okay, now let me create my text splitter. Now inside that, I'm going to provide my data. Now it will give you chunks. Now let me see how many chunks I got. So here I got 86 chunks. If you want to see them, simply just print like that. Let's say I want to see the first chunks. This is the first chunks. Let's say I want to see the second chunks as well. I can also see that. See, second chunks as well. And you can see it is also giving me the source URL, like from which URL it is giving you the data. Okay. Now we'll be initializing the embedding model, because you can see the architecture. Now I have to download the embedding model, then I have to convert everything to the embedding representation. So let's use the OpenAI embedding. Now let's test whether it is able to convert to the embedding representation or not. So here I'm calling the embedding model and I'm passing one sentence, hello world. So it should give me the embedding results. Let me show you. And the vector dimension is 1536. Okay, this is the dimension. Now if I show you the numerical representation of this sentence, so this is the numerical representation. That means this is my vector embedding. Okay, so we'll be following the same concept. Now let me convert my text to the embeddings. But for this, actually, I'm going to use FIAS vector database, because whatever embeddings I'll be generating, I'll store in the FIAS. Okay, FIAS vector database, and FIAS is a local vector database. I think you know. So here I'm giving my text chunks and my embedding. Okay, embedding model. Now guys, see, this is my semantic index right now. Okay, this is my semantic index. That means my vector index right now. Okay, now what I have to do, I have to connect my large language model. So let's initialize my large language model. So here I'm going to use OpenAI large language model. By default, it will use GPT 3.5 Turbo. Now let's test our large language model, whether it is able to generate or not. So here I've given a prompt. Please provide a concise summary of Harry Potter book. Okay. Now if I execute, it should give me the summary of Harry Potter book. See, this is the summary of Harry Potter book. Okay. It has given me. Great. That means it is working fine. Now with the help of LLM as well as my vector database, I have to create my chain. So for this, I'll be using retrieval keyway with source chain. Okay. I think I already imported from the LangChain. And inside that, I'm passing my large language model as well as my vector database. Okay. And this will give me the chain. Now inside chain, actually, I can ask any kinds of question right now. See, question is equal to how good is Vicuna. So here I'm asking related Vicuna. Okay, this particular Vicuna. So Vicuna data I have already given to my large language model. I think remember it is already available inside my knowledge base. Now it should give me the answer. Okay, let's see. Okay, now if I want to see the answer, so I'll just call result. Inside that, I want to only extract the answer. Okay, now let me show you. See, Vicuna has shown competitive performance compared to the others model like Stanford Alpha. Okay, that means if you read it, okay, if you read this documentation, you will see that that is what actually they're telling. That means amazingly, it is able to give me the answer right now. Great. Now let's ask any other question. Let's say the next question I'll be asking about Llama 2. Llama 2. How does Llama 2 outperforms other model? Okay, let's ask this question, and whatever answer I will get, I'll also print it here. Now see, Llama 2 model outperform other models in various categories, including MPT models and similar size and so on. Okay, now see, it is referring the Llama 2 right now. Yeah, Llama 2. Great. Now let me ask another question. So I'll be asking about MPT, this one, MPT 7B model, and whatever results actually I will get, I'll just showcase it here. See, again, I got the amazing response. Okay. Now see, it is referring my website data. That means my custom data, not any other data. Okay. This is the main thing here we have developed. Now, if you're asking any other question, let's say, tell me about India, it won't be giving you the answer, because here we have created the custom chatbot. It will only refer my data, the custom data I have given. Now here I can create a while loop and I can continuously ask the question. Okay, so you can see I'm taking the prompt from the user, and if it is exit, I'll do the exit operation. Otherwise, I'll continue and I will keep on asking the question and it will generate the answer. Okay, let me show you. See, it is asking the question. So what I can give the same prompt again, copy, and here I can pass. And let me press enter. Now what you can do, guys, you can convert this project to the web interface. That means web application. I think I showed you how we can use different, let's say, Python package like Flask, then Fast API. So this should be your task, guys. Try to create one web application, at least basic web application. Their user will give the prompt and it will provide the answer. Okay, that's it. Now see, it has given me the answer. Okay, now again it is asking another question. Now let's say if I give exit, it will exit the application. Sorry, it should be exit only, but I have given exit parenthesis. Now see, if I'm giving this prompt, it is telling that text provided does not seems to be relevant to the questions. Now see, this question actually doesn't have any context, whatever knowledge base it is referring. That's why I told you it won't be able to give you any other information. Now if I give exit right now, it should exit the application. See, okay, so that's how we can create any kinds of custom website with the help of our custom data. Now what you can do, you can open up any kinds of website and you can implement this project, guys. Okay, and later on I will also tell you how we can use the open source large language model. Okay, and with that, how we can create this application. So with that, guys, thank you so much for watching this video, and try to complete that task. Try to convert this application to the web interface as well.
So guys, as of now, we have worked with OpenAI based large language model, which is nothing but GPT. Okay, so we have seen like how to use GPT series to build this kinds of generative AI application. And one thing I think you have seen there, like GPT is not free, so you need to pay for it. So whenever you are using OpenAI API, you need to pay some money, okay, for that. But let's say if you don't want to spend this much of money here, so what you can do, you can use something called open source large language model. So in the market, actually, we have lots of open source large language models are available. So if you are using it, so you don't need to pay any money for this. So you can directly use them, and it is completely open source and for commercial use cases as well. You can either do research on top of it. You can either create a commercial application on top of it. It's completely free for you. Okay. So in this video, actually, I'll be discussing about like open source large language model, like what is open source large language model. Okay. And what are the open source large language model we have, and from them actually I'll be discussing some of them, like most popular used open source large language model, and it is like very powerful. Okay, and I will also show you how we can like build generative AI application with the help of these kinds of open source large language model. Okay, so it would be completely amazing video, so make sure you are watching this video till the end. Don't skip any part of this video, otherwise you might get confused for sure, right? So yes guys, let's start with our video. So guys, here we'll be learning like most used and most popular, very powerful large language model. Here you can see we have Meta Llama 2. So this is the model from Meta AI. I think you know, like we also call them Facebook. So they have introduced this model called Llama 2. It has another version called Llama 1, but Llama 1 is for like research purpose. They have given the permission, but you can't use Llama 1 for the commercial use cases. So for this, actually, they have open sourced this Llama 2 model. So you can either do research on top of it, either you can create commercial application. It's completely fine. Then from Google side, we have another large language model called Google Palm 2. So this is one of the very powerful large language model. Okay, and it is completely open source and free. Then we have another like most used large language model called Falcon. So Falcon has lots of variant. I'll show you like whenever I'll be discussing like Falcon, I will tell you like what the variant it has actually. So it has different parameter variant. Okay, even Meta Llama 2 has different variant. Okay, I will tell you whenever I will discussing about this Llama 2 and all. Okay, so these are the most used and most popular large language model. I'll be discussing like how we can use it, okay, and how we can create generative AI application on top of it. I will be discussing each and everything. So apart from that, we have lots of large language model are available in the market, and it is completely open source. So guys, I found one GitHub repository. So there actually that guy collected lots of open source large language model list, and he has created one readme file there. So I'll show you that one, like what are the open source large language models are available in the market. So if you also want to explore that one, you can also go ahead and check it out. Okay, so if you learn like how to use Meta, Llama 2, Google Palm 2, Falcon, okay, you will also able to do that. Okay, so guys, as you can see, this is the repository, and the repository name is like Open LLMs. And here if you see, we have lots of open large language model are available. You can see T5, EUL2, then Pathia, DALL-E. Okay, then here you will see like Bloom is there, then fast chat, then MPTP 7B. This is the 7 billion parameter. Then Falcon, I will be discussing about Falcon. So as you already saw, like in my topic, I will be discussing about this Falcon. Okay, so even that, actually they have also shared this paper blog and everything. Okay, if you want to learn, you can open it, and all these steps actually will be getting. Then Llama 2 is also there. Okay, then Mistral 7B also there. Then Google Palm is also there. Okay, so here actually we'll get all kinds of open source large language model. Okay, and if you see here, it was committed 4 days ago, so it is like very update repository. So here you can check it out if any large language model is coming in the market. So here actually will get all the list and all. And apart from that, you can also search from your side. Let's say if you are exploring any other topic and all, so you can search and you can learn about. Okay, so yes guys, this is all about our large language model, open source large language model. I think you got it. Okay, so guys, we don't only have the option using like you can say OpenAI GPT model. Apart from that, we have these kinds of open source large language model we can utilize. Okay, so I personally prefer this kinds of open source large language model because this is like very powerful. So it can also work like your GPT 3.5 turbo. Okay, so it's like very powerful model. So using these are the model, actually you can solve a very complex problem statement. Even you can create a very beautiful generative AI application. So why you need to pay, right? But if you also want to pay, because see, GPT is like very good model, I know that, but again it's like completely hosted like API. So you can directly call the API, you can hit the model, you can get the response. So this is the beautification they have created in their website. But apart from that, let's say you don't have money and you don't want to spend money on top of these kinds of model, so you can use these kinds of LLM model and you can create your application on top of that. Even you can also fine tune them. Okay, so this is the beautification of these kinds of large language model. So in future, I will also show you how we can fine tune these kinds of large language model on top of our custom data, on top of our custom use cases, and how we can use it. Okay, so fine tuning is not required unless and until your data is like very complex and it is like very private data. So that time you can fine tune them, but most of the use cases can be solved using these are the model. Okay, so yes guys, now let's go back and try to see like what are the things actually we'll be learning from this video. So guys, in this video actually I'll be discussing like the introduction to Llama 2, like what is Llama 2 and all, like who has published this Llama 2, like what are the variant actually Llama 2 has and all. Then I will show you like how we can run this Llama 2. Okay, I'll show you like some difficulty level, like how why we can't use the actual Llama 2 model, okay, hosted from Meta AI. So which model actually I'm going to use it. So how to execute this Llama 2, okay, I'll be discussing about on Google Colab, because you can also do it in your local machine as well, but I will do on Google Colab because Google Colab would be pretty much good environment for me, because there I will already have lots of predefined library setup, right? Then I will show you like how we can use this Llama 2 with Langchain, because nowadays actually people uses this Langchain's framework, okay, to create generative AI application. So I'll also show you how we can use the Langchain, okay, with this kinds of Llama 2 open source large language model. And at the end of the video, I will also show you how we can build generative AI projects using Llama 2. So there actually will be implementing one project, so very interesting projects, okay, with the help of this Llama 2. Even I will be using Langchain there also, okay. Then we'll see like how we can integrate open source model with this kinds of framework Langchain, then how we can create these kinds of generative AI projects. So it would be completely end-to-end video about this open source large language model. Okay, you'll be learning each and everything about open source large language model, like you will be knowing each and every part of this Llama 2 and all. So make sure you are watching this video till the end. So this should be my request guys, and also try to practice with me, okay, in live. Whatever things I'm writing, you just also try to write with me. Even all the code and everything will share in the resources section. From there actually you can get it. So first of all, let's discuss about Llama 2, and in the next video, I'll be discussing about Google PAM and Falcon. So guys, if you search on Google like Meta Llama 2, so you will able to see this website, the first website, okay. So this is the website of Llama 2. So here actually they have published this Llama 2 documentation and all, like how we can use it and all. And this documentation will give you the entire idea about Llama 2, like what is Llama 2 and how many variants actually it has, okay. Even the benchmark also you will able to see. So guys, here if you see Llama 2 is nothing but it's a next generation open source large language model, and Llama 2 is available for free research and commercial use cases, as I was discussing about. And if you want to access this Llama 2, so they have given the link here. So here actually you need to fill some information like your name, email address, then country and organization. So these are the basics form you need to fill and you need to submit. So after some time, actually, they will give you the permission, because see, you can't directly use this Llama 2 model. So for this, you need to send some information of you. Then after some time, actually, they will give you the permission. Okay, I also applied this request form. So after, let's say 30 minutes or let's say 1 hour, you will get the access for sure. Okay, so I will also show you one alternative. So if you want to do it right now, so one guy actually cloned this complete Llama 2 model, okay, in his you can say Hugging Face repository, and it is completely public. Okay, so you can use that model if you're not getting permission. And once you got the permission, you can use official version of the Llama 2 model. Okay, so I'll show you like both option how we can do it. So for me, I already got the access from this Meta, so they have given me the access. I'll tell you like how to apply for the access and all. Okay, so as of now, the experiment actually I'm going to do, like how we can execute this Llama 2 model. I'll be using something called quantized model, because the actual like Llama 2 model you can't execute on Google Colab, on free Google Colab. So for this, actually you need good instance. Okay, like good instance means like you need powerful machine, you need more RAM. Okay, you need more memory there. But if you are using free version of Google Colab, and if you're using your local system, so there actually you can't load this model, so it would be very hard for you. So better we'll be using some quantized model. I think you know what is the quantized model. So quantized model is nothing but it's a quantized version of the actual model. So they have just compressed the model, okay, with the integer encoding, and they have proposed this model, and this model size is a little bit less, so we can load this model in our memory, okay, in very easily. I will tell you like how to use a quantized model and all. Okay, so guys, here if you see, Llama 2 was trained on 40% more data than Llama 1. Okay, because I told you there is another model called Llama 1, and Llama 2 trained here Llama 2 trained actually more than 40% data than Llama 1, and it has actually double context length. So, basically the context length is like double, okay, than your Llama 1. And see, these are the Llama 2 variant. Actually, Llama 2 has 7 billion parameter, and another variant has like 13 billion parameter, and another variant has 70 billion parameter. And this is the pre-training token, you can say. So they have used true trillion token to train this model. And here if you see, this is the context length, so it's 4096, but whenever I was talking about Llama 1, so it has actually 2000 something context length, but it is like double, okay, double than your Llama 1, and this size is around 4096. And here if you see the training strategy, so they also use supervised fine-tuning technique on top of it. Then they also use something called human preferences. I think you know like how we can train these kinds of large language model. Okay, what is the idea and all about. Basically, this is the strategy we follow in every large language model. Okay, then they have applied something called reinforcement learning to understand the human input, to understand the human you can say prompt. Okay, so they have used this strategy to train their entire model. And Llama 2 pre-trained models are trained on 2 trillion tokens. Here I already discussed, and have double context length than Llama 1. Its fine-tuned models have been trained over 1 million human annotation. Okay, so 1 million human annotation means they have applied this supervised fine-tuning technique. So they have created one chat use cases. So basically, see, whenever I'm giving any input, let's say just fix this code for me, or let's say generate you can say a Python code for me. So these are the chat actually I'm giving. So with respect to that, actually, what is human annotation? Human annotation means like see, whenever you are giving these kinds of prompt, so one human will be replying the actual thing here. Okay, that's how your model will be learning. Let's see, if you're giving any random message, let's say hi, how are you, fine, okay, and all. So one human will chat with you, like manually they will chat with you. So we call them human annotation, and with the help of this data, actually we train our actual model, and we create these kinds of very powerful large language model, right? And this is the benchmark, as you can see. So here we have lots of model. We have MPT 7B, then Falcon 7B, and we also have our Llama 2 7B 13B, and we also have 65B and 70B. Okay, so here we see these are some benchmark data, and this is the performance of the model. As you can see, MPT 7 billion, this was the accuracy, 26% accuracy. And here if you are using Falcon, so 26.2% accuracy. And if you're using Llama 2 7B here, so see, accuracy is like very much increased here. It's around 45.3% of accuracy. And if you're using 7B, that sorry, and here if you're using 13B, that means 13 billion parameter version of the model. So here this is the accuracy, 54.8% of the accuracy. And here if you're using MPT 30 billion, so this is the accuracy. Then I mean, it's like less than your Llama 2. And Falcon 40B actually will give you 55.4%, and if you're using Llama 65 billion, so 63.4%, and Llama 7B like very good accuracy here, 67.9% of accuracy. Okay, so with respect to that, you can see this is again another data. So this is like MMLU data, so this is trivia QA data, this is natural questions data. So you have lots of benchmark data. With respect to that, these are the model has been trained, and this was calculated the accuracy. Okay, and this is the complete benchmark table. Here you will see all the performance of the model. Okay, and guys, if you want to test this Llama to a model, so here there is a one UI has been published here. If you see on top of the Llama 2 model, so if you just write www.llama2.ai, so this is the chatbot actually you will able to see. So this is kinds of ChatGPT kinds of interface they are providing, and in the backend actually they are using Llama 2 model here. If you see, so you can select Llama 2 model, different model. So by default it is selected Llama 2 7 billion. So let's select this one, Llama 2 7 billion parameter, this model. And you can also give the your system prompt here. So let's take this prompt only. And the temperature you can also select. Let's say if this temperature is close to 0, that means this model would be more strict to the output. So it won't give you any randomness. And if you set this temperature as close to 1, that means your model will be like more random. So it will give you like more random output. Okay, and if you want to make your model like more generalized to randomness, so you can increase this parameter to close to 1. And this is the max length, like how many output you want from your model and all. So you can set this parameter and all. And this is the top probability score and all. Okay, so here you can write your custom prompt as well. Let's say here in this case I'll be doing chat operation with this Llama 2. Here if you see chat with Llama 2, you can also set this prompt as summarization, let's say code generation, anything you can do. Okay, so you need to just change this prompt. I think you know what is prompt and all. So this thing is very common, okay, in LLM and all. So you can give the prompt here. So let's take this Llama 7B parameter, this model, and let's do some chat with this model. So here first of all, let's say I will just write hey or let's say hi. So here if you see, this is giving me the response. Okay, now here I can ask like what is the library we can use to build Gen AI application. I'm just giving any random question. Let's see whether it is able to uh, answer or not. So here if you see, it's giving different answer, okay, with respect to the question I have asked. Now let's say here I can also give any error of my code, and if I tell it actually just try to solve this error. So let's say I was trying one OCR code here. So this is the error actually I got. So let me show you the error. So guys, this is the error actually I got here. So could not find a version satisfied the paddle. Okay, this is the error I got. So this error actually I will ask to this Llama 2, and let's see whether it is able to fix or not. Here I will just write fix it. Okay, if I just write fix it, now let's see what happens. So guys, see, it is giving me the response, and it's telling like install this version of this paddle. Okay, and you can also use some third-party GitHub to build this setup tool and all. So it's giving all kinds of possibilities, like you can try, you can get this suggestion and you can try and you can solve this error. Okay, so Llama 2 is telling actually this model is like more powerful than GPT 3.5 turbo model. Okay, because see, I already used this Llama 2 model, and what I feel like, yeah, this model is pretty good than your GPT 3.5 turbo. If you're using GPT 3.5 turbo, you saw like lots of task actually it won't be able to solve in a good way. But if you're using Llama in this case, Llama 2 in this case, actually it can solve like various kinds of tasks. Okay, so this is the playground you can play with this Llama 2 model. You can select different version of the model, and you can play with this model. All kinds of question you can ask, and you can realize like how powerful this model it is. Okay, so yes guys, this is all about our Llama you can say introduction and all. I think you got it, like what is Llama 2 and all. Okay, the basics overview, you got it. Now I will show you like how we can use this, how we can run this Llama 2 model on the Google Colab. So guys, for this actually I already prepared one Google Colab notebook for you. As you can see, this is the Google Colab notebook, And here we'll be learning like how we can execute this Llama 2 model on the Google Colab. So as I already told you, we can directly load this Llama 2 official Llama 2 model from the official Llama. You can see it. This Llama 2 is available on this Hugging Face. So from Hugging Face itself, actually you can see this Meta AI Llama. Okay, and this is the Llama 2 model. This is the original Llama 2 model, official Llama 2 model. It is hosted on Hugging Face. From here actually you can load this model, but this model actually I can't load in my free Google Colab. For this actually you need good instance, good memory, good GPU and all, but here I'm using free Colab, that's why I can't load. And you can also load this thing in your local machine. Okay, so for this actually what you need to do, you need to use something of quantized version of the model. So again, Hugging Face also provides like quantization model. So some of the actually organization have already applied this quantization technique, and they compress, these are the actual model, and they hosted on the Hugging Face community. So here if you see, we have like various kinds of quantized model. Here if you see, so these are the quantized models. So this is the, so here guys, if you see, this is the ggml format of quantized version of the model. And if you see, like lots of model are available. Okay, so from this model actually I'm going to use one particular model. So this is the model link I have given, just let me open it. So the model name is Llama 2 13 billion chat ggml. Okay, ggml is the format of quantization, and this is the organization. So this organization has quantized this model. Okay, and it is published here. Now this model is like more like a small model, okay, than your actual Llama 2 model, which is published on Hugging Face. This model actually you can easily load in your free Google Colab. Okay, or if you're using your local system as well, you can also load there. Okay, and this model has lots of variant here. If you see, the bin means this is the model. Okay, this is the bin format of the model, that means binary model. So from these are the model, I'll be using one particular model because these are different quantization you can say format. So I'll be using one particular quantization here, and this is the size of the model. As you can see, this is the size of the model, and after applied quantization, this size has been reduced. Because what is quantization? Quantization means all the weights you have in the model, by default it would be floating number. Okay, but if you apply quantization on top of it, it would be converted to integer, and your size would be reduced. Okay, your model size would be reduced automatically. So this is the like idea of quantization model. So here your accuracy might decrease, but again you are like getting the faster model here, you are getting the small model here. So this is the idea. Okay, and if you want to use actual this meta llama, or that means this Llama 2 model, so here actually you need to get the permission. You can directly access this model. So let's say if I open this link in a different, or let's say incognito window, so you will see it will ask for the permission actually, because I'm using my account there, so that's why you can't see the permission. Now see here, if you see access to access Llama 2 on Hugging Face, so here first of all you need to log in with this website. Okay, if I click on this login, so it will ask for just logging with your Hugging Face. So here you need to first of all log in with your Hugging Face. Let's say I will log in with my Hugging Face here. Okay, now see here I have already logged in, that's why it's telling like permission granted. But for you actually it will show like you need to apply for the access. Okay, so whenever you will apply for the access, so it will give you that form. I think you remember, it will give you this kinds of form. So you need to fill this form. Okay, and you need to select all the information. So you can select like which model you want to use. So you can select both of them, and you can just send the request. Okay, so after some times you will receive one mail like that. So after some times actually you will see one mail like that. Let's say I applied for this access. So this is the mail I got. So hi puppy, this is let you know that your request to the access model Meta Llama 2 on the Hugging Face has been accepted by the author. Okay, so once you got the access, then you will able to see this kinds of window here. This kinds of window here, gated model, you have the granted access to this model. Okay, but initially whenever you will be applying, so it will take some time, at least 1 to 2 hours, then it will give you the access. But if you want to try okay this model, so again I will tell you another option, because this model is available on the public repository as well. Okay, because see, in Hugging Face we have two kinds of repository. One is like organization repository, that means private repository. If you want to use private repository, so you need to like take the permission from the author. And one like you have like public repository. So in public repository actually you will have the access to the model. You don't need to take any permission from the author, they will by default provide the access and all, so you can directly use that. So one guy actually cloned this entire model, and he has published from his account here, and I will be using that model. Okay, same model only, but this is the unofficial and that is the official one. Okay, I'll tell you like whenever I'll show you like how we can use this Llama 2 model with the help of Langchain. At that time, I will show you like how we can use it. But as of now, let's try to run this quantized version of the model. As I already told you, I'll be running this quantized version of the model, which is nothing but this model. If I show you, this is the quantized of the model. Okay. And guys, Meta AI actually also provides like different version of the Llama 2 model, as you can see. So we have 7 billion, we have 13 billion, we have 70 billion. So in this case, actually, I'm running this 13 billion. So you can't execute this 13 billion in your free collab. That's why we are using quantized version of the model. But in our next experiment, so whenever I'll be using Langchain over there, so I'll be using this 7 billion parameter model, and this model actually you can easily load in the Google Colab or your local system as well. Okay, so for this model, I'll take the permission and see, guys, these are the model are hosted. Now if you see, these are the model are hosted from the Llama 2. As you can see, chat model, HF model. I'll tell you like whenever I will be using these are the model, I'll tell you. So yes, guys, this is all about. Now let me just quickly show you like how we can execute. So see, to execute like quantized model, you need one library called Llama CPP. Okay, so this is the library actually you need to use. Llama CPP is a library. Actually, this library helps you to make the quantized of the model. Okay, and if you're using quantized version of the model, you need to install this library. So first of all, I will connect this notebook. Now make sure you have selected runtime as GPU. So just click here and click on manage GPU. Sorry, not here. Just click on the runtime and select here you will get one option called change runtime type, and I have already selected GPU here. So now if you want to check whether you've got GPU or not, so you can execute this command, and here you will see I got Tesla T4 GPU, and it has actually 15 GB of like VRAM. Now here these are the requirements actually you need to install. So first of all, I am installing this one Llama CPP library. Okay, and this is the command to install everything. And here I am also installing Hugging Face Hub, because from the Hugging Face itself I want to access this model, because see, this model is hosted on Hugging Face, and if you want to access any Hugging Face model, so you need to install Hugging Face Hub. And here I'm also installing Llama 2 CPP Python. Okay, so these two commands actually you need to execute to install Llama CPP library. Then I also need NumPy with this specific version. Now let me execute. So guys, as you can see, my installation is done. Now here you just need to give the name of the model, like which model you are using. So here, this is the model I'm using. Just copy this name here, and here you just need to paste it. Okay, so I have just given this name here. Now here you also need to specify the base model name, like which particular model you need to use. So here I'm using Q5.1.bin model. So if I go here, so it has lots of variant, I already told you. So here I'm using this Q5 this model actually, I think, let me just see, q5_1.bin, q5_1.bin. Yeah, so this is the particular model actually I'm using. So you can use any model, no issue with that. So I'm using this model, and this is the size of the model. So I'll be executing. So you need to give the same name, just copy paste from here and just give it here. Now once it is done, now so here first of all I'll be importing one class called HF hub download. That means Hugging Face model download. So this class will help you to download any particular model from the Hugging Face. First of all, let me import. Then I also need to import this Llama from Llama CPP library, because we have already installed this library. So let me import it. And if you're not using quantized version of the model, okay, you don't need to install this Llama CPP. So we can directly download the model from Hugging Face. Okay, I'll tell you whenever I'll be using this model actually, because I already told you Llama 2 provides lots of version of the model. Whenever I'll be using smallest version of the model, I'll be directly downloading the model from the Hugging Face. Okay, at that time I don't need this Llama CPP library. Okay, but here I'm using quantized version of the model. That's why this needed. Now, first of all, you need to download the model. To download the model, first of all, you need to give the repo ID. Repo ID is nothing but your model name. So this is the URL I'm giving. Okay. And you also need to give the file name, like which particular file you need to download. So here you need to give this base name here. Now it will automatically go to the repository and it will automatically download for you. See guys, it's downloading, and this is around 9.76 GB. So let's wait. It will take some time. I'm able to load this model because here if you see my VRAM, GPU VRAM, I got 15 GB. That's why I can load this model very easily. That's why actually I'm using this quantized version of the model. But if you're using actual this model, if I show you actual 13 billion parameter llama 2 model, okay, without you can say quantized model, so it is more than your 9 GB and you can't load it. Okay, that is the issue actually. So I'm following this approach. See, this model has been downloaded. Now if you want to see the path of the model, like what it has downloaded, so it has downloaded in this folder actually in my machine. Now first of all I need to load my model. To load the model actually, first of all I'll be defining one class llama. Actually you have seen like we have imported the llama, and here you just need to give the model path. So this is my model path here I have given, and these are the parameters you need to keep it. Okay, these are the default parameters you need to keep it. Now let me execute and load the model. So guys, as you can see, my model has been loaded. Now here you can also check like the number of GPU layer you have in your GPU. So we have 32 layers. And now first of all I'll be creating one prompt template, because we don't directly give the prompt to our LLM. We also create a prompt template. Okay, so we won't be directly asking the question, because let's say what kinds of question actually you want to ask to your LLM, you need to specify using the prompt template. I think you are already familiar with what is prompt template and all. So here I have created one prompt template. So this is my prompt. This is the question of the user. Just write a MNIST image classification code in Keras, and here is the prompt template. So I'm telling my LLM. So here I'm telling to my LLM as a system means it will consider I'm telling to my LLM. And here I'm telling you are a helpful and respectful and honest assistant. Always answer as helpfully. Okay, this is my prompt template. And here I'm giving one example. So user will ask these kinds of question, and you need to give the answer as an assistant. Assistant should be the response from my LLM. Okay, so this is the prompt template I have created. Now let me execute. Now here I'm initializing my LLM. So here I'm giving first of all my prompt template. Then I'm also initializing the max tokens. Max token means like how many output you wants from your model. You can, if you're using GPU, so you can decrease this length. If you're using GPU, you can increase this length. Okay. Temperature, I think you already know. If it is close to 0, that means you are taking like more streak output from your model. And if you are increasing to 1, that means you are taking the randomness from your model. But here I have set 0.5, so it's middle position, and this is the top probability score, and these are some default parameter you need to give. Okay, now let me execute it. So it will take the prompt and it will understand the prompt template and it will give you the answer. So here I have written like write a MNIST classification code in Keras, so it will give you the code with respect to that. And this model is pretty huge, that's why the response time is a little bit high, so you need to wait for some time. So guys, execution done. Now let me print the response I got. So this is the response, but it's not readable. So from this response, I only need to see the text from my model. So let me execute. See guys. So here I got the answer. So here if you see, this is my system. That means this is my prompt I have given to my model. And this is the question user has asked, and this is the response I got from my assistant. So first of all, it's telling hello. I would be happy to help you your MNIST classification projects using Keras. Before we begin, may I ask what specific aspect of the projects you need to assistant with do? Do you any prior experience with the deep learning and Keras additional? So it's giving some output. So what you can do, you can again execute this code. I think it will give you that, because if you're using for the first time, I think it will give you that response. Now let me execute for the second time. So guys, now you can see it has given me the code for the MNIST image classification. Now let me give another prompt. So here I will just write a linear regression code. Write a linear regression code. Let's see like whether it is able to give or not. So I'll again execute. Now guys, I got the response, and guys, this is the code for linear regression. Okay, so it's amazing guys. So we are getting our output, and yeah, so that's how actually we can use our llama 2 model. Okay, llama 2 model we can run, and this is the quantized version of the model. Again, some accuracy might be less. Okay, you might get some wrong output because of the quantized version of the model. Okay, but again, it's a pretty good, you will get all of the response. Okay, whatever question you are asking. Now what I will do, this was like how we can execute like quantized version of the model, because I was using because here I was using llama to 13 billion parameter this model. But next, actually I'll show you like how we can execute using a Langchain. Okay, how we can use using Langchain. So there actually I'm going to use this model called 7 billion. So 7 billion parameter this model actually I'm going to use. Okay, and this model has actually lots of variant. Okay, I'll tell you. So we'll be using some HF version of the model. Okay, then I'll show you like how we can load this model. So yes guys, this is all about this execution of this llama 2 model on Google Colab. Now let's explore like how we can use this llama 2 model with the help of Langchain. So guys, now let's see like how we can use llama 2 model with the help of Langchain framework. And we have already seen like how we can execute this llama 2 model on Google Colab. So there actually I used like one particular model, so 13 billion parameter model. But there actually I used something called quantized model, because I can't load this 30 billion model, okay, in my free Google Colab. I think I was already discussing about. Okay, but in this example I'll be using this 7 billion parameters. So this model would be a little bit small for me to load in my memory. So I can load this model, okay, in my free Google Colab. There is no issue with that. But again, to load this model, you need to take the permission from Meta AI. Okay, this model is available on the Hugging Face website. I will tell you like why you can get this model. So if you search on Google like Llama Facebook research, so you will get this GitHub repository, and there actually they have mentioned everything about Llama 2 and all. And they will also give you the download link and all. So if you click on this download link, so you will redirect to this page, and here you just need to fill out this information. Okay, so I think I already showed you this thing. And they have already written like how we can access this model from the Hugging Face also. See, this model is also available on the Hugging Face website, so you can visit Hugging Face and see it has this three variant like 7B, 13B and 70B. I think I was already discussing about. And again, if you see here, these are the model has lots of sub variant like llama 2 7B chat model, llama 2 13B HF model. Okay, so these are the like sub variant of the model. So this is nothing but like some of the model would be bigger, some of the model would be smaller. Okay, so that's how they have trained different model with respect to these are the variant of the model. Okay, now here if you see here in the GitHub, they have written one thing. This llama 2 comes with two different model. One is like pre-trained model, and another is like fine-tuned chat model. So what is pre-trained model and what is this fine-tuned chat model? So pre-trained model is nothing but these model are not fine-tuned for the chat or question answer. They should be prompted so that expected answer is the natural continuation of the prompt. So basically what they're telling, actually with this pre-trained model you can't do actually chat operation, or you can't do actually question answering operation, right? Like the way we usually perform with our LLM model, we ask any question, we do the chat operation with that. So with this pre-trained model you can't do. Let's say if you want to generate text, or if you want to, let's say, generate something, okay, from the model, you can use this kinds of pre-trained model. Okay, and what is this fine-tuned chat model? So this fine-tuned chat model were trained on dialogue applications, so to get the expected features from and performance for them, with specific format defined chat completion. So basically what they're telling, so with this fine-tuned chat model, actually you can do the chat operation. Let's say if you want to do any question answering, if you want to perform a chat operation, you can use this fine-tuned chat model. So in this example, I will be using this fine-tuned chat model because I want to perform chat operation with the LLM. Okay, I want to ask some queries and all. So I'll be using this model. But let's see if you want to generate text and if you want to generate something, so you can use this pre-trained model. Okay, so now if you visit here in this Meta Llama 2 on Hugging Face, so they have different model, as I already told you. So it has chat model also, and it has without chat model also. So now you can choose any of them. Okay, so guys, from these are the model itself, I'll be using one particular model. So I'm going to use this particular model called llama 2 7B chat HF model. So here is the model description and all about, you can read it out. Okay, so with this model actually you can do chat operation and all. Okay, and this is 7 billion parameters, so I can easily load this model in my free Google Colab. Okay, so there is no issue with that. I don't need to use any you can say quantized model, okay, from them. So now what I will do, Before loading this model, you need to take the permission from the Meta AI. So what you need to do here, so you will see one option here, just apply for the permission. See, for me, I have already applied for a permission, and they have already given me the access. That's why it's telling you have been granted to this model. Okay, so I already have the access to this model. But if you're doing it for the first time, make sure you have applied for the permission. Okay, so once you get the permission, so you will get this kinds of message here. If you see here, you will get this kinds of email like you have granted to this model and all, so they will mail you with respect to that. And once you click here, so you will redirect to this kinds of form. So here you just need to, these are the form, and submit your information. So after some times, actually they will give you the permission. But if you're doing it right now, and if you're waiting for the permission, so what you can do in between, I will show you another option. Okay, another alternative I will show you. So that alternative you can follow. And guys, one particular thing you will always need to remember, so whenever you are submitting the request, okay, whenever you are submitting the request for this model, make sure the email address you are using, the same email address you are used in your Hugging Face as well. Okay, so the same Hugging Face email address, okay, you have created your account, so same email address you need to submit here. Okay, as you can see, you need to submit your email address here. So make sure you have selected the correct email address with respect to your Hugging Face account, so that you will get the quick access there. So guys, I already created one notebook for you. So here I will show you the demo how you can use this Llama 2 model with the help of Langchain. And I think you already know what is Langchain. Langchain is nothing but it's a framework for developing application powered by language model, or you can say we can also develop generative AI application with the help of Langchain. And this is the Langchain documentation and GitHub I have already given here. You can go and check. And if you don't know like Langchain, so we have a tutorial in our YouTube channel. Just go ahead and try to finish that lecture. Otherwise, it would be a little bit difficult for you to understand like what I'm trying to say, right? So guys, here I'm already expecting you are familiar with this Langchain framework, like what is chain, what is prompt template and all about, okay? So this should be the prerequisite for this video. Now guys, the first thing what I need to do, I need to connect my notebook. And make sure you have selected runtime as GPU, because you need the GPU to run this model. So change runtime to GPU. So for me, I have already selected. And let me connect the notebook. So guys, notebook is connected. Now, first of all, let's see whether I got GPU or not. So this is the command to check the GPU. So here I got Tesla T4, and here I got 15 GB VRAM. Now what I need to do guys, I need to install some of the libraries. See guys, if you're using any open source large language model, okay, open source LLM model, which is available in Hugging Face. So for this, actually, you need to install this transformer library. Okay, so using this transformer library, we can actually access our Hugging Face model. Okay, so that's why this transformer library we need to install. Then I need to also install, these are the two libraries, Accelerate and Anops. Then I need also Langchain, because here I'm going to use Langchain. Okay, and this Bison's bytes. Okay, so these are the packages actually I need to install. So these are the actually dependency. So Langchain I need because I will be running these at the LLM model, Hugging Face LLM model, with the help of Langchain. And I also need transformer, because I will be using my Llama 2 model from my Hugging Face itself. Okay, that's why this transformer is required. Now let me install. So guys, as you can see, installation is done. Then first of all, what I need to do, I need to log in with the Hugging Face account. Okay, so to log in with the Hugging Face account, you need to use Hugging Face CLI to log in. Okay, so here you just need to give the API key. Okay, Hugging Face API key. So there is a secret key actually will get from your Hugging Face account. So let me open with my Hugging Face account. So guys, this is my Hugging Face account. If you don't have any Hugging Face account, just try to create one account. Okay, now if you click on the profile and go to the settings, and here you will get one option called access token. Okay, just click on the access token. So here previously I already created one access token here, so I'll be creating a new one. So you can also create a new access token. You can give any name. So let's say I will give as Llama, and you can get read and write permission. I will be giving read permission because I only want to read the model from here. Then I'll just generate a token. So this is my token guys. Now what I will do, I'll just copy this token. And guys, don't share this token with anyone. Okay, otherwise they will also able to access your account. So I'll remove this token after this recording. Okay, that's why I'm showing. Now let me execute this command, and it will ask for the token. So just click here and paste your token and just press enter. So if you do it, so now it will tell add token as get credential. So what I will do, I'll just give yes and press enter. Now guys, here if you see my logging is successful. Now what I will do, I will import, then I need to import this Hugging Face pipeline from Langchain, langchain.llms, because with this Hugging Face pipeline, so with the help of this Hugging Face pipeline class, I will be loading my large language model, which is nothing but my Llama 2. Okay, so I need to import this library. Then I also need to import tokenizer. So what is tokenizer, guys? Tokenizer is nothing but it is responsible for pre-processing the text into arrays of number as input to the model. Because so whenever I will be giving any input to my model, it would be completely text input, right? But my model can't understand that text, raw text actually I will be giving. So for this actually what I need to do, I need to convert to numbers, right? Even I also need to perform some pre-processing. So everything can be performed using this tokenizer, okay, auto tokenizer class. So that's why I need to import it. Then I also importing transformers, then torch and these warnings. Okay, now let's load our Llama 2 model from this Hugging Face. So as I already told you, so you will get these kinds of access once you got the access and all. Okay, so I have already added some screenshot here, and once it is done, it will tell you this message, right? Now here guys, you need to define the model actually you want to use. So in this case, actually I'm using this model. As I already told you, I've just copied this name and just paste it here. If you see, this is the complete name I have given. And this is the model from Meta, because this is the official model actually I'm going to use. And this model I need the permission. I think I already told you this model I need the permission. But let's say if it is taking for you to take the permission and all. So what you can do, you can use this model. You just comment this line and uncomment this line. So this is the same model, but this is present in the public repository, and this access is given to everyone. Okay, so you can easily use this model, and this is the same model, guys. Okay, this is the same version of the model. So what this guy has done actually, so he has cloned the official version of this Llama 2 7B chat agent model, and he has published in his you can say repository here, and this is completely completely public access, so you don't need to take any access okay from this author, so you can easily use this model. So let's say if you have applied for the access and it is taking time and you want to do it right now with me, so what you can do, you can uncomment this line and you can load this model. Okay, but for me I have already access to my official model, so I'll be using official model and I will comment it out. Okay, so it's up to you which model you're going to use. Now guys, first of all, what I need to do, I need to load my tokenizer. So to load the tokenizer, you need to give the same model name. Okay, so with respect to that, it will load the tokenizer. Now here, what you need to do, you need to create one pipeline objects, and here you need to call this transformer pipeline. Okay, and here you need to give the pipeline name. So here I have given text generation, because if I go to this model I'm using, so this is a text generation model. As you can see, this is a text generation model. So that is why I have given text generation here. Now I also need to give the model, like which model I'm going to use. So this is the model I have given here. Okay, then I'm also need to give the tokenizer. So this is the tokenizer I have given, and these are the parameters. Just keep it as default, and this is the maximum input length. So I've given 1000. You can also increase and decrease the size. Okay, it's up to you. Now guys, what I will do, I'll just quickly load my pipeline. So basically it will load the entire pipeline. It will load your model, it will load your tokenizer, everything it will load as a pipeline. So what is the use of this pipeline? Pipeline means, like, first of all, whenever you are giving any input to the model, first of all, it will apply the tokenizer and it will convert that text to numbers. Okay, it will pre-process the text, then it will apply this data to the model. Okay, so that's why this pipeline handles each and everything. You don't need to write any custom code for it. And now guys, here if you see, it is downloading the model. Okay, and I'm using free collab, and I got 15 GB VRAM there. So I think you can see RAM is not utilized till now because it is downloading the model. So once it will load the model, it will utilize my RAM. So guys, my model has loaded. Now what I need to do, I need to call this Hugging Face pipeline. I think you remember we load this Hugging Face pipeline from Langchain. Okay, here if you see from Langchain .llm, so we load this Hugging Face pipeline. Now I need to give this pipeline object to this Hugging Face pipeline from my Langchain. So here you will get two parameters called pipeline. So here you just need to provide the pipeline. Okay, this pipeline we have created. And another keyword you need to give the temperature value. So what is temperature value? So see, I think you already know like what is temperature value. So here I've already written. So temperature value, like so if it is 0, that means the model is very safe and it is not taking any bets. And if you are giving this and if you're setting this value to close to 1, so it will be taking risk. Okay, and it might generate wrong output, but it is very creative. So this is the parameter actually you can change. Let's say if you want some stick output from your model, okay, you can set this parameter as close to 0. And if you want, let's say, very creative results, and you are not worrying about the wrong output, or let's say random output, so you can give this parameter as 1. Okay, so this is the parameter you need to give. So here I want streak output from my model, that's why I set this parameter as 0. Okay, so this is the parameter I have given. Now here I'm defining as LLM, so this is my large language model. Okay, but I think you remember initially I was using something called OpenAI large language model, which is nothing but GPT 3.5 turbo. You can use anything, GPT 3, GPT 4, anything you can use. But there actually I was using OpenAI API, and it was taking charge from me, right? But this is completely free. Now see, with the help of these kinds of open source large language model, and it is also available inside Hugging Face, we have easily loaded this model. Okay, and we have created our LLM object here. Now this is one prompt actually I have prepared. So what would be the good name for a company that makes colorful socks? So this, let's say this is my prompt, this is the user prompt, this is the user input, and it is giving this input to the LLM. And now let's see like what LLM will predict. Okay, so here I will give this prompt to my LLM, and let me execute. You can also set your custom template, prompt template. I will tell you like how to set it, but first of all, let's give my prompt without any template, because by default your LLM will have some like you can say default template, it will use that template. So guys, here is the response I got from my Llama 2. So I would suggest the following names for the company that makes colorful socks. So Sol Mats, Hue and Cry, Tall, Tally, Socks. Okay, it's great actually. Even it is giving also the description with respect to the name it is suggesting. Now you can give any kinds of prompt, you can check it out. So let's give another prompt. So here I have given, I want to open a restaurant for a Chinese food. Suggest me a fence name for this. Okay, so you can also give, let's say, Indian food. Okay, I'll give Indian food. Now let's see whether it is giving me some name or not. So I'll execute my LLM. Now guys, as you can see, it has given me the name. So restaurant, I would suggest the following names for your Italian, for your Indian food restaurant. So Tandoor Nights, then Spice, Rahut, Mumbai, Bazaar, Curry Leaf. Okay, so great. I am getting very good name. Let's see if you want to open a restaurant. So you can refer, these are the name, and these are the name is like very unique. Okay, and this is the description. Now also you can create your custom prompt. Let's say see, this is the better practice to create our custom prompt always. Let's say whatever task you want to perform with the help of your LLM, so you can give the custom prompt, okay, instead of using the default prompt. So to give your custom prompt, you need to import prompt template from Langchain first of all. So let me import, and I also need to import something called LLM chain, okay, from Langchain. Now this is the first example I have given. So this is my prompt template one. So here I've given the same prompt as I think you remember, and I've just written I want to open a restaurant for here I've given cuisines. Cuisine should be the input. Okay, here I've given this should be the input variable. Food, suggest me a fancy name for this. Now I'll be using this prompt template, and I will be giving to my LLM model. Okay, so it won't be using that default prompt template after giving it. Now let's say how it will work. So this is the technique it will work. So basically it will apply this format on top of it, and whenever it will get this cuisines, actually it will replace this input. Okay, the input I have given, let's say I've given Indian. Now if I print this input prompt, if you see I want to open a restaurant for the Indian food, search me a fancy for this. Okay, so this is the input I have prepared with the help of this code, right? Now let's take the second example. So this is the another prompt I have created, prompt 2, and here I'm using another prompt, provide me a concise summary for this book, and here I'm taking book name as input from the user. So how it will work, so whenever user will give any input, let's say I have given Alchemist book. Okay, so it will take as input, and it will make the complete prompt. See, it will make the complete prompt. Okay, now let's use the first one first of all. So I'll be using this from template 1. So here just let me write. Now I'm going to use this prompt 1 at the very first. Let's use prompt 1, and here I have created LLM chain, and here I have given my LLM. Okay, so LLM model I have given, so which is nothing but the LLM we have created. I think you remember, this is my LLM, this is my LLM. Okay, and here I have given the LLM, and here I'm giving the prompt as my prompt template, and here I'm also giving verbose is equal to true. That means it will also print the log, like what it's doing actually. So if you're making it false, so you can't see the output log, and if you are making it true, so you can see the output log. Okay, now here you need to call chain.run, and here you just need to give the input. Okay, so here let's say I'm running this prompt 1, and this for the cuisine. So here what I'll give Indian cuisine. Okay, and this is the response I will get. Now let me execute and show you. See, first of all, it is entering to new LLM chain prompt after formatting. So this is the prompt it has prepared. So it has taken my input Indian, and this is the prompt actually it has created. Now it is applying LLM on top of it, and it will predict. Now let's see. Now guys, chain has been finished, and this is the response I got. A restaurant name is a crucial aspect of any business, okay? And these are the name actually it is suggesting. Now what I will do, I'll give this prompt template 2, that means my book prompt, and here now I'll ask any book name. So let's say I'll give Harry Potter. Harry Potter book. I want the summary of Harry Potter book. Let's see whether it is able to give or not. And this model is pretty good, guys. Just try to explore this model. I am loving this model a lot. Okay, as an open source model, I can say like this is one of the best model you can use from Meta AI. So see guys, this is giving me the summary. Again, if you mention the book with a specific name, let's say it is giving the summary of Philosopher's Stone. Okay, you can also give any specific book. It will give you the summary. In that summary it will give you. Okay, so great guys, we are able to use this Llama 2 model with the help of Langchain, and we have seen like how we can load this model with the help of Langchain and all, how we can create the template. Okay, how we can create the LLM chain and everything we have seen, right? Now guys, it's time to make one projects with the help of this Llama 2. Now what I will do, I will create one chatbot projects with the help of this Llama 2 and Langchain. So basically, we'll be creating one chatbot so that can chat with any kinds of website. So let's say if you have any website, okay, so you can integrate that website to your chatbot. So whatever question user will ask with respect to the website, it will give you each and every answer. Let's say this is one website, Llama Meta website, okay. So let's say I want to ask any questions, okay, from this website. Let's say I want to ask like what this website provides, okay, what are the services it provides, give me the contact information and all. So that chatbot will able to give me everything with respect to the website I have. So this kinds of chatbot actually will be implementing with the help of this Llama 2 and Langchain, okay. And I will also utilize like a vector database with that projects, okay, because I have already explained like vector database. So I already created one dedicated session on vector database. Just go ahead and check it out if you haven't checked it out, that session. So guys, we'll be using everything like vector database, this Llama 2 and Langchain. With the help of that, actually we'll be implementing this entire projects, okay. And this is going to be one very interesting projects, okay. You will be enjoying a lot. So now let's start with the projects and let's see like how we can develop these kinds of generative AI projects. So guys, now let's build one generative AI projects, one generative AI application with the help of large language model. So here I'm going to use Llama 2. And here I'm also going to use some of the additional tool. Let's say I'll be using vector database, then I will be using Langchain framework, okay. Then we'll be implementing this amazing application. So the application actually I'm going to implement called website bot. So what is website bot? I think you have probably seen like if you visit any kinds of website, so some of them are already created some bots. So if you ask them question in the website, like what this website and all about, like what are the services it provides, so everything it will give you the answer, right? Whenever we visit any website, let's say I will visit openai.com. So if I visit this website, so if you want to see this website structure, like how many pages actually it has, and like what is the layout of this website, what are the URL of that page, actually everything you can see, okay. If you visit this link called sitemap sitemap.xml, okay. If you just write this one, sitemap.xml, and if you press enter, so it will give you all the detail about this website. Let's say this is the website, and it has actually different pages. If you see, if I go to again OpenAI, if I go to OpenAI, so if I let's say click on research and click on let's say overview, so it will open a different tab for me. Like let's say this is the different page for this website. So that's how actually you have different website, and with respect to that, it has the different links as well. As you can see, different links actually it will also provide, okay. Let's say this is another page, okay. This is another page inside OpenAI. So let's say I'll copy this URL, and if I paste it here, so it will open that particular see it is opening that particular page, okay. So that's how actually you can export with any kinds of website. So I already collected some of the website URL. So what I will do, I will use that URL and I will build this application. So here if you see, I've already prepared one notebook here, and here I already collected some of the website links. So if I open it, so see, this is one blog website link. So paper review, Llama 2 open foundation fine-tuned chat model. So it has some content. Okay, it has some content. So we'll be chatting through this content, like what are the things actually this content is providing. Okay, everything we can ask in our bot whenever we'll be completing this thing. Not only this thing, I have attached multiple URL. As you can see, this is another link. Okay, this is another link, this is another website. So again, some content is inside that. Again, it has different pages. As you can see, it has different pages. It has different pages. If you just visit that site map.xml, you will see different pages link, you will see there. Then I also have another one. So this is the website of stability.ai, and again actually it has some content. So you can give any kinds of website link here. So I have collected these are the website link, so you can use any of them. So here is another website. Okay, so we will be using this 4 website URL, and we'll be implementing one website bot on top of it. So let's say if you're asking anything, okay, if you're asking anything regarding these are the 4 website, like what are the content, everything, like what are the things actually it is providing, what is this, let's say if you want to ask something about Llama 2 open foundation fine-tuned chat model, you can ask, so it will give you the answer with respect to the content actually it is giving. Let's say if you want to ask like PT7B, okay, this is another open source large language model. If you want to ask something, so here you can ask, so it will give you the answer with respect to this content. So any website you can refer. Let's say if you have created your custom website as well, so you want to create one bot on top of it. So let's say I'm the user, so I will come to your website. First of all, I will ask to your bot like what are the services actually provide, what are the things actually provide. I can get all the information from your bot. Then I don't need to visit your website, okay, again and again. So I can ask everything from the bot itself. So guys, this is going to be one amazing projects, and what you feel like, just try to comment in the chat. Okay, so whether it's helpful or not, and make sure you are just watching this video entirely, don't skip any part, otherwise you might get some issue. So guys, now what I will do, I will first of all give you the project's idea. I'll be just giving you the project's architecture. I'll be just writing the project architecture, like what are the steps actually we're gonna do throughout this entire projects, like what are the component we'll be implementing. Okay, so we'll be seeing the project architecture at the very first. Then once you understand this architecture, we'll be moving to the coding part. So let's go to our whiteboard and try to understand the project architecture. So guys, I'm inside my whiteboard. So now, first of all, I will just write the project's name. So it is website bot using Llama 2. Okay. So here, let me give you the project's architecture, like how we are going to do the project. So first of all, what I will do, I need to collect those website sitemap.xml. Basically, I need to collect all the content, okay, from the website actually I'm referring. So first of all, we'll be taking all the content with the help of this sitemap.xml. Okay, xml. And you don't need to worry about manually, you don't need to write these are the thing. Actually, if you're using Langchain, so with the help of Langchain, actually you can easily extract the content from any unstructured website. Okay, I'll tell you like how to do it. So what it will return, it will return so it will return you page, okay, page, let's say 1, page 2, and page 3. So after getting the page, actually I need to get the documents, okay, present in the page. So it will return me the documents. Let's say docs, okay, docs 1, docs 2, docs 3, okay, docs 4, and so on. So docs 4, okay. Now it will return me that documentation, like all the page content. So once I get all the content, okay, basically here let me write out here, we are just extracting text, okay, extracting text. And after getting all the text, what I will do, I will use my embedding API, that means embedding model. So in this case, I'm going to use Hugging Face embedding model. I think you already know what is embedding model and all. I already discussed this thing in my vector database session. So if you haven't watched that session, you can go ahead and watch it. So everything would be clear there. So I'll be using embedding model. So with the help of embedding model, actually, I'll try to convert this text to vector. Okay, vector representation. Now this will return me the vectors. So here I will get lots of vectors. Then once I get the vector, I will build one. Build semantic index. Okay, I think you know what is semantic index. Semantic index means you will be combining all the vector together. Okay, then we will be building the semantic index, and you will be storing this semantic index to the knowledge base. Okay, so what is knowledge base? Knowledge base is nothing but your vector database. So let's say this is my knowledge base. Okay, this is my knowledge base, or let's say vector db. So these are the vector will come here. These are vector will come here, and it will store inside my vector db. Okay, so once I'm able to store, these are the vectors, okay, in my vector db. Now what will happen? Let's say this is the user. Let's say this is the user. So user will hit some queries. So let's say this is the question from the user. So the first thing what I need to do, I need to convert these questions to the vectors, because again it's going to be the raw text. Okay, so again I will be applying something called embedding model. Okay, then I'll convert this text to vector. So here I will get something called query embedding or query vector. So this query vector, I will apply something called semantic search. I think you already know what is semantic search. Okay, so semantic search on top of my vector db. Okay, so I'll do the semantic search. So once you do the semantic search, it will return you some ranked result. Okay, rank results. Now I will have my rank results. Now I will take the help from my LLM. I'll be using large language model, which is nothing but my Llama 2. Okay, here I'm going to use Llama 2. So with the help of this large language model, I will get my actual response. Okay, the query user has asked, so it will give me the actual response. Okay, so this is the complete idea, and this is nothing but this is my user. This is my user. Okay, so this is the complete you can say diagram of our projects. As you can see, first of all, we'll be using, these are the website. With the help of sitemap.xml, we'll be extracting all the pages available in the website. Then we'll be extracting the documents. That means extracting the text. After that, we are just converting. Let me write here. Converting text to vectors. Okay, here we'll be converting text to vectors. Then we'll get our vector embedding. That vector embedding will be building one semantic index, and we'll be storing into the vector db. So in this case, actually, I'm going to use something called Pinecone vector db. Okay, you can use any vector db. Weaviate, you can use ChromaDB. You can also use Face, okay, from Facebook. Anything you can use, but I will be using Pinecone. Then what will happen? User will ask some query. I will be applying again embedding model, and I'll be getting query embeddings. And with the help of this query embeddings, I'll be do semantic search on top of my vector db. It will give me rank results, and with the help of LLM, I'll extract my correct output I was expecting. Okay, and it will give me the correct response to the user. So this is the complete idea of these projects. Now what I will do, and here I already prepared one notebook for this project. So I'll just explain like whatever things I have done. So first of all, I need to connect my notebook. Make sure you have selected runtime as GPU. So here just click change runtime type and select GPU. So for me, I have already selected. Now here I need to install some of the package. So here I'll be installing Langchain, then bytes and bytes accelerate transformers. Why we need it, I think you remember. I think previous experiment I was showing how to use Llama with the help of Langchain, okay, and I was reading that Llama model from my Hugging Face, and for Hugging Face actually I need to install these are the libraries. Then these are the actually dependency you can install, okay. Then PyPDF should be another dependency, and also you need to install sentence transformer. Now let me install them. So installation is done. So here I'm not going to use OpenAI. So let me just delete this thing. Then I also need to install this library unstructured because the website will be loading. So it has lots of unstructured format. So to overcome this thing, actually you need this package called unstructured. So let me install it. I'm not using FICE. FICE is again another vector database. So you can remove this thing. I'll be using something called Pinecone. So this is done. Then I also need to install tokenizers. Then Xformers as well. Now I will be also installing Pinecone client because here I'm going to use Pinecone vector database. And guys, if you haven't checked my vector database session, you can check it out. Okay, it is available. Otherwise, you might get some confusion. So it's better to try to understand this vector DB. Okay, then you will get the entire idea. Now, all the things I have installed. Now I'll be installing all the requirements libraries actually I'm going to use, and whatever libraries actually I'm going to use, I will tell you, okay, which library actually I'm using for which purpose actually I will tell you at that time. So here you can see some additional library also I'm importing, but again I will discuss like what are the things actually I need here. Now I also need to install punctuation NLTK. So the first thing I need to collect some of the website URL. The website URL actually I want to use for my bot. So here I already showed you I am using this 4 website. Okay, I'm using this 4 website. You can use any of the website and you can use it. So these are the 4 website link I have provided inside one variable called URLs. Okay, now let me execute. Yeah. Now I think you already saw we have imported one class called unstructured URL loader from Langchain. Here if you see unstructured URL loader. So this class will help you to extract all the data from this or the URL. Okay, I think I was explaining this project architecture, like it will be using something called sitemap.xml. Then it will extract the pages. Okay, from the pages it will extract the documentation. So everything can be done with the help of this function actually we have imported here. Okay, unstructured data loader, and here you just need to give the URL, and it is not only working with the single URL, it will also work with the multiple URL as well. Okay, so now if I execute and show you, so it will easily extract the data, and it will go through all the pages actually this website has, and it will extract all the data for me. See, it has extracted. Now if I print my data, see guys, all the data you can see here, it is amazing, right? So that is the power of Langchain. So that's why we use this Langchain framework to build this kinds of generative AI application. Okay, now if I show you my data length, so it should be 4 because I'm using 4 website, so it will give you 4 website data. Okay, here now this data should be in a document format. I think if you see the format of this data, it should be a document format. Okay, and now I need to apply something called text split on top of the entire corpus I have, because I need to convert my data to chunks. Okay, why I need to convert my data to chunks? Because see, I think I already discussed this thing in my vector database session. Why this chunks is important? Because whenever you open any kinds of model, okay, let's say if I open let's say OpenAI model here, OpenAI model, OpenAI, or let's say if I open my Llama 2 model. So here if you see, it has context length as 4096. Okay, like it can take like 4096 tokens, okay, at a time. But if it is more than that, actually at the time your model can't take this and it will give you error. Okay, but the data actually we have extracted, it has like more than 4096 you can say tokens. Okay, so that's why I can't directly pass this data. I can directly pass this corpus to my model. So that's why I need to convert to chunks. Chunks means I will be converting different chunks. Okay, different chunks means different paragraph. Okay, and that paragraph I will be converting to like embedding vector. Okay, then I will be giving that data to my model. Okay, I already discussed this thing in my vector database session. Just try to go ahead and check it out. This should be very much clear. Now here I'll be converting my entire corpus to the chunks. So this is the character splitter function I have imported from Langchain. Here if you see character splitter from Langchain I am importing. Now with the help of this one I will be creating the entire chunks. Now here you need to provide two things, the chunk size and the chunks overlap. Chunk size means like how many tokens you need in a chunks, and chunks overlap like how many tokens actually you want to consider from your previous chunks. Okay, so these two parameters you need to give here. Now let me execute. Now my chunks object is created. Now I'll give my data. I'll give my entire data I got from my URL, and it will convert it to chunks. Okay. Now if you want to see the chunk size, so it has created 90 chunks. So if I print my text chunks, okay. So now let me show you. See, this is another chunks. Then again, this is another chunks. Okay, then again this is another chunks. That's how it has created 90 chunks. Okay, and if you want to see individually, you can also see this is the chunks 0, chunks 1, and if you just read it carefully, you will see some of the tokens are coming, okay, from your previous chunks as well. Okay, so this is the chunks overlap. So basically it helps us to understand the context of the sentence actually you have. Okay, now we have successfully converted our entire corpus to chunks. Now I'll be downloading the Hugging Face embedding, because here I was discussing I got my all the documents, okay, and I have converted to chunks. Okay, if you see, we have converted to chunks, docs1, docs2, docs3, and docs so on. Now I need to use Hugging Face model, Hugging Face embedding model, to convert these chunks into embedding, okay, vector embedding. So that's why I will be downloading first of all Hugging Face embedding. So to download the Hugging Face embedding, I think I already imported this library here. Hugging Face embedding, I think somewhere, yeah. So from Langchain embeddings, Hugging Face embedding. So it is available inside Langchain. Now here I'm importing. Okay, now if I execute, it will automatically download the default model. So Hugging Face has lots of you can say embedding model. So this is the one of them. Okay, so this is the name I have already given. You can open it up. So this is the model for embedding. Okay, so you can read about this model. I have already downloaded this model, and now let me see the model, which model I got here. So here if you see, I got something called sentence transformer all MPNet base v2. This is the model I got. Okay, this is the embedding model. Now if I, let's say if I want to convert any text to embeddings, okay, and I want to see like what kinds of vector and what is the length of the vector, so I can test it. So let's say I have given hello world, and from the embedding I'm just doing query embedding. Now see guys, the length should be 768. Now this is the vector representation of this sentence. Okay, this is the vector representation of the sentence. So you can give any here. So let's say I'll give hello, or let's say how are you? How are you? And I have explained this thing detailedly in my vector database session. So that's why I'm again and again telling you, just go ahead and try to check it out, that video. This should be very much clear. See, again, I'm getting the same length, like 768. And this is the how are you vector representation. Okay. Now what I will do, I will initialize my Pinecone vector DB. So for this, actually, I need to collect two things. One is like Pinecone API key, and it is like Pinecone API environment. So for this, I need to visit first of all Pinecone. So just write pinecone.io, and here make sure you have the account. So I have already account, so I'll just log in with my account. So guys, if you log in with your accounts, you will able to see this kinds of interface. So first of all, you need to get the API key. Just click on the API key, and here is my API key I have already created. So what you can do, see, this is my previous API key. I will just copy this API key, and if you don't have API key, just create it here. Okay, just click on create API key, give the name, and create the API key. Will get your API key. Then I'll just paste this API key here. So this is my API key, and don't share this API key, guys. I'll remove this after this recording. That's why I'm showing. And I also need like a Pinecone API environment. So for this, actually, you need to create one index. Just click on the indexes and create an index. And you need to give the name of the index. So let's give Llama projects. Llama or you need, let's give Llama, only give Llama. Okay. And here you need to give the dimension of the vector. So this is the dimension actually. So here I'm using Hugging Face embedding. So Hugging Face embedding, this is the dimension 768. So this dimension I need to give it 768. And I will take this cosine metric. Okay, so you have any other metric as well, so I'll use this cosine metric, and because here I'm using free plan, then I will create the index. So it will take some time to ready your indexes, so let's wait. See, once it is done, it will give you this green icon. Now here you will get this environment name called GCP starter. Okay, I will copy this name, and here I need to give it. Okay, done. Now let me execute. So I have set my environment, so API key and API environment. Now I'll initialize my Pinecone. So here, instead of giving inside your ways, you can give it directly. It is also fine. So let me just give it directly. So that's how I can provide. Now let me execute. And now I will give this credential, and I will just initialize my Pinecone. And here you need to give the index name you have created. So this is my index name, which is nothing but Llama. I will copy, and here I'll just give the name. Okay, and this particular line will convert your entire like chunks to the embedding, vector embedding, and will store inside the Pinecone. See, this is the code. Basically, I have my text chunks, and one by one I am just reading the content, and I am using my embedding. Okay, and I'm converting to vectors, and index I'm giving also, like this is the index, like this is the index I have created. So in this index, actually your vector will store. Now let me execute and show you. Done. Now if I go to my Pinecone and refresh the page, you will see like all the vectors actually. Okay, see, this is my text. With respect to that, this is my vectors. Okay, this is the vector representation, and this is the index. Okay, and now see, we have successfully stored our data. We have successfully stored our vectors to the vector database. Okay, and you can see all the vectors here. Okay, you can also query out everything you can do, and this thing you can learn from my vector-db tutorial. So there actually I have showed you like how to use this vector-db and all. So here I'm not going to explain in depth, okay, because they are already explained this thing. Now see guys, I already stored my vectors inside my vector-db. Now what I will do, I will first of all logging with my uh, uh, this one, my Hugging Face, because I want to use that Llama 2 model from Hugging Face. For this actually I need to log in. So let me log in. So if you want to log in, you need this access token. I think you remember I was collecting the access token. So this is my access token. I'll just copy. You can create your access token. Okay, I think I already showed you how to create it. Now here I just need to give the token and login. See, logging successful. Now here you need to specify the model name, which model you want to use. I already told you I'll be using this Llama 2 7B chat HF model. So this is the model name I've given here. And you can use that alternative also. Like let's say if you don't have the permission, you can use that model, that open source model. I think previous experiment I was showing, okay? Because I already have the access, so I'll be using this model. Now, first of all, I'll load my tokenizer and model. I already discussed like what is tokenizer and model. Okay, why I'm loading? Because I want to create the pipeline. Now let me load it. See, it is downloading the model. So it will take some time. Let's wait. So guys, we have already downloaded the model. Now we need to create the pipeline. I think I already showed you like what is pipeline and all. Okay, why we need it. So now let me initialize the pipeline. Okay, so here if I show you my diagram, so we have completed till this point. Actually, we have stored the data. Now we are initializing our LLM. Okay, then we'll be handling the user. Now pipeline has been initialized. Now I'll be calling this Hugging Face pipeline, and inside that I will give my pipeline objects, and I will also give this argument called temperature. I already told you what is temperature. Now let me initialize my large language model. Okay, now let's first of all test it whether it is initialized successfully or not. So here I'm giving one prompt. Please provide a concise summary of the book of Harry Potter. So it should give me the summary. So guys, as you can see, we are getting the output. That means my LLM has been initialized and it is working fine. Now let's do some question answer with my LLM. The data we have given, like the website we have given. Okay, so from the website we can ask any kinds of question. Now first of all, I need to import this retrieval QA. Okay, this function. Now here, this is my query. Like I'm just asking how good this Vicuna. Okay, so there is another website, actually, I think you remember. This is all about Vicuna. So I want to ask something about Vicuna, okay, from this website. So it will give me the response, okay, with respect to that. Now this is my question. Now this is my query. If I perform something called similarity search on top of my vector DB, so it will give you three different results, as you can see. I think I already discussed this thing, like similarity search, how to perform. And now let's say if you want to get the actual results, okay, actual results with respect to your questions, so you can take the help from the LLM. So that's why you need to call this retrieval QA, and here you need to initialize the LLM, chain type, and retrieval. You need to give your vector store object here, okay, and as retriever, so it will, so basically it will refer your vector database, and it will also take the query, and it will understand the query with respect to that. It will also understand the question you have asked, okay, the documents response you got, then it will give you the authentic results. Okay, now let me initialize this one. Okay, yeah. Now I will ask the same query, like how good this Vicuna. Now if I ask this query to my LLM, see, it will give you the answer. So guys, as you can see, it has given me the answer. Vicuna is a chat bot that uses stable diffusion 2.1 generate the response while its quality is high. Okay, it is giving this response. Now I'll ask another question, like how does Llama 2 outperforms than other model? Let's see. Because if you see here, I have another website of Llama 2. So this is the Llama 2. Okay, so I'm asking uh, the question with respect to that. Okay, so this is the power of this LLM, and we can create these kinds of generative AI application with the help of this Llama 2, Pinecone, and Langchain. See guys, Llama 2 outperforms model benchmark. Okay, so it is giving like GPT-4 PAM2. Okay, basically, yeah, this is the response it is giving. Now let's ask another query, like what is stable LM. Okay, I think again, if you see, like I am also passing one question with respect to other website. See here, you can also add your custom website. You can ask any kinds of question with respect to that. See, this is the response I got. Now you can create one while loop, like ask the question repetitively one by one. So now it will ask for the user input. Now here I will ask one query, like what is MPT7B. So I think you remember we have one website of MPT7B. Okay, now let's ask one query on top of it. So yes guys, as you can see, I got the answer. MPT7B is a 7 billion parameter language model developed by LLM Foundry. Okay, it is giving all the answer. Now you can ask any kinds of question. You can give, see again, it is asking for the prompt. So I won't be asking, I'll just write exit. So it will exit my code. See, here I have written the logic. So yes guys, I hope you got it, like how we can implement these kinds of beautiful generative AI application with the help of Llama 2, Pinecone, and Langchain. Okay, so this project actually you can also convert to Streamlit app. In future, I will also show you how we can convert it to Streamlit app. Okay, and whenever I will show you like end-to-end project implementation, I will show you that part. So yes guys, I think you have liked this particular session, and you have learned everything about Llama 2, like open source large language model, how to run it, and how we can also implement this kinds of generative AI application. So if you have liked this particular video, just try to share with your friends and family, and if you need anything from my side, you can let me know in the comment. Okay, so guys, as of now we have seen like various kinds of open source large language model. We have seen like how to use Llama 2, how to use Google PAM2. So in this video, I'm going to discuss another open source, very powerful large language model, which is nothing but Falcon. So guys, this is another open source large language models. Even Falcon has lots of variant like, so recently Falcon has published this 180 billion parameter, this model, but it has some other variant as well. Here if you see, Falcon has actually 1.3 billion, 7.5 billion, 40 billion, and this is the recent one, which is nothing but 180 billion parameter. So actually I can't load this 180 billion parameter with this Google Colab and all. So if you have good instance, so you can load it, process would be same, but I will take this model guys, 7.5 billion, this model, 7 billion model, and I will show you one demo like how we can use this Falcon open source large language model to build our generative AI application. So first of all, I will show you like how we can integrate this Falcon 7B model with our LangChain. So we'll be seeing like how we can perform inferencing on top of the model. Then I will also show you how we can create generative AI application on top of that. So guys, here if you see, Falcon is nothing but it's a open source large language generative AI model. And if you see here, Falcon helps us to create a very advanced application, and it has actually lots of version like 180 billion, 40 billion, and 7 billion, and 1.3 billion parameter. And it is trained with high quality like data set, so that actually it can perform all kinds of job, okay, whatever you will be giving as a prompt. So we'll see like how we can do it. And it has actually, these are the variant, as I already told you, 14b, and even they have already given you the download guideline and all. So to download this model, actually I'll be using Hugging Face, because Hugging Face has already this kinds of model hosted here. If you see, this is the Falcon 7b instruct model. So this is the 7 billion parameter model, so I'm going to use this model. So you can use any other model as well. Let's say if you want to use this 14 billion model, okay, just try to search here, you will get the model. So in this example, I will show this model, okay, I will use this model and I will show you the demo. So for this, actually I have already prepared one notebook. As you can see, now this is the notebook I prepared. So first of all, let's see like how we can perform the inference on top of this Falcon 7b model, okay, with the help of Langchain. So for this, first of all, make sure you have connected your notebook and you have selected GPU as a runtime. So I've already selected. So as of now, whatever things we have learned like Llama, then Google Palm, all the steps are same only, okay, but only you just need to change the model there. So this is the idea here. So if you're using any kinds of large language model, not only Llama, Google Palm, or let's say Falcon, if you're using any kinds of large language model, I already showed you, right? Like I already showed you, like we have different large language models, so all the process will remain same. You need to call the same method and all, okay, if you are using Langchain and all. And the way I imported my model here, you can easily load it, okay. And you can refer some documentation, because whenever, let's say, you are referring any kinds of large language model, they will have their documentation. You can go through the documentation, you will get the idea. And guys, throughout this entire session, actually I showed you 3 large language model, like Llama to Google Palm and this Falcon one. And rest of the large language model you can explore, all the process will remain same, okay, only you just need to do some exploration on top of it. So guys, here if you see, I already connected my notebook. Now if you want to check the GPU, whether you got GPU or not, this is the command to execute, then you will see the GPU. Then first of all, I need to import some of the libraries, because here I'm using like a Hugging Face model. So for this, actually I need to install transformers, and these are the libraries, okay. Then I will be also using Langchain, so I also need to install Langchain on top of it, okay. So let me install them. So guys, as you can see, installation is done. Now I will be loading the model. So guys, to load the model, if you're using Hugging Face model, so first of all, you need to call this Hugging Face pipeline from Langchain, as well as you also need to call the tokenizer, okay, and the pipeline objects. Now here is the name you need to define. So this is the name I've just copied from here and I pasted here, okay. This is the name, and if you're using some other model, you can change the name here, so it will automatically download the model. First of all, you need to define the tokenizer. Tokenizer will help you to convert your text to numbers, okay, and it will also do the pre-processing steps before feeding the data to the model. Then I will initialize in the pipeline. So it's a text generation model, that's why I have given the text generation. It will take the model, it will also take the tokenizer, and these are the parameters you need to keep it as default, okay. Now if you execute this particular code, so you will be able to see like it will first of all download the model. So guys, this is the model size, around 9.95 GB. So let's wait, it will take some time. So guys, as you can see, my model has downloaded. Now I need to load this model. So I need to load this pipeline object actually. So to load this pipeline object, first of all, I need to initialize this Hugging Face pipeline. I think I already imported, you saw that, Hugging Face pipeline from Langchain. Then here I need to give my pipeline, and here one parameter I need to set called temperature. So temperature, I think you already know what is temperature. Temperature means like if you're setting it to 0, that means your model would be like very strict, and it won't be taking any risk whenever it will give you the response. But if you're setting it to 1, so it will take risk and it will give you some random output. That's why you need to think about like whether you need very creative results or random results from your model or not, okay. If not, then try to keep this value close to 0. Otherwise you can keep this value close to 1. So here I've given 0 because I want strict output from my model. So let me initialize my LLM, okay. Now here, first of all, I need to initialize one prompt template, okay. Then I'm also initializing LLM chain, okay. So let me import them. Then this is my template, custom template I have defined. So you are an intelligent chatbot, help the following questions with the brilliant answer. So here you will get this kinds of question, you need to return this kinds of answer. Okay, so this is the custom prompt I have created. Now this prompt I will initialize with the help of prompt template. It will take the template and it will also take the input variables. In this case, input variable is my question. Now let me initialize my template. Now first of all, I will initialize my LLM chain. To initialize the LLM chain, first of all you need to give the prompt and as well as your LLM. Okay, then it will give you the LLM chain. Now this is my LLM chain. So here is a question I'm giving. Explain what is artificial intelligence as nursery rhymes. So it should give me that explanation. Okay, so here I'm just writing LLM chain.run and here I'm giving my question. Now let me execute and show you. And if you see here guys, my memory is getting full because I loaded this 7 billion parameter model. So that is why I was telling like you can't load this 180 billion model because it's like very huge model. For this you need good system. You should have good GPU and good memory there. But all the process would be remaining same. Okay, only just need to change the model name there and everything will remain same. So guys, here is the answer I got. A child may be small, but with a AI can do all. Computers and machine learn faster and faster, allowing the child to great heights. So this is the response I got from my model, and with respect to this nursery rhymes. And you can ask any kinds of question, like let's ask another question. So I'll copy this one, and here I can ask, give me a code for adding two numbers. So here if you see it can also generate code. So any kinds of prompt you can give, any kinds of task you can do with this LLM. Let's say you want to do summarization, generate text, generate poem, generate code, anything you can perform with this model. Okay, and it's like very powerful model guys. Even you will be loving a lot after learning this one. Okay, I think you got the idea. Now guys, in future I will also show you how we can fine tune this LLM. Okay, like we have learned Llama, then Google Palm, then Falcon. We can also fine tune them with respect to our custom task. Let's say you have some complex data and this task your model can't perform. So at that time you can also fine tune them. So in future I will also show you like how we can fine tune them on top of our custom task. Okay. But guys, all kinds of tasks actually these are the model can perform, so you don't need to even fine tune them because fine tune is not easy, so it like more costly. So I'll always suggest just try to use this at the model. Okay, these are the trained model. So and you can perform your job here, and you can also give the custom data, like I already showed you like how to put the custom data on top of that, like how to perform these kinds of operation, how we can do the information retrieval operation, how we can perform the summarization, everything I have showed. Even in future I will also create some of the videos, like we'll be implementing some projects. So and we'll see there like how we can create end-to-end generative AI application with the help of these are the LLM model. Now guys, this is the inference on top of this Falcon 7B. Now let's create one project with the help of Langchain. So here I'll be using ChromaDB and we'll be creating one multi-doc retrieval system. So basically here we'll be giving some documentation. In the documentation we'll be doing the information retrieval operation. I think we already saw in our Google Palm one. Okay, there actually I was using PDF, but here we'll be using the textual data. So for this actually, first of all, I need to install, these are the libraries. So let me install them. So I need to first of all terminate my previous instance. Done. Now let me install them. So here I'm using ChromaDB. So you can use any kinds of vector database. You can use Pinecone, Weaviate, anything you can use. And I'm also using Langchain. So we are installing Langchain transformers. We are also installing because we are using Hindface, and we also need sentence transformers. Okay, so everything we need to install here. So if you have already watched that Google Palm video, so this notebook will be mostly familiar with you because I'm referring the same code only, but only here I'm using Falcon model and I'm also changing the database here. Okay, only this part I'm changing. So installation is done. Now I'll be importing these are the libraries. So I'm importing ChromaDB, then recursive character splitter, the retrieval questionnaire, text loader, and directory loader. So first of all, I need to download the data. So this data is available in this URL. So I'm first of all downloading this zip file. then I'm performing unzipping operation on top of it. See, if I show you the data, so guys, this is the stock market data. So it has lots of stock detail like Nvidia stock, then Tesla stock. So these are the txt file data. As you can see, these are the stock data. So on top of that, we'll be performing this information retrieval operation with the help of this LLM. Now first of all, I need to load this data, then I'll be extracting that text. So this is the code for it. Then if you want to see the documents, like the final data you got, so these are the data I got. Now what I need to do, I need to perform this text splitter on top of it. Basically, I want to convert my entire corpus to chunks, okay, because I already told you what is chunks and all. So my model has like one particular input size. If you see the documentation, so if you're using this one, Falcon 7b instruct, so it has some particular you can say input size, input token size, so you need to give that particular size. So it's better to convert to chunks, so that this kinds of problem you won't be facing, okay, whenever we'll be feeding the data. So let's convert to chunks. So that many of chunks I got, 49. Now if you want to see some chunks, so this is the code for it, okay. So see guys, all codes are same as I already used in my previous experiment as well, okay. That's why I'm just going a little bit fast, because I think you got the idea like how we are performing these are the operation, right? Now here, first of all, I will initialize my Falcon 7 instruct model. The same way I'll be using, I showed you in that previous notebook, right? Yeah. So it will first of all download the model from the Hugging Face. So it will take some time. Let's wait. So my model has downloaded. Now let's import my Hugging Face pipeline and Hugging Face embedding. Because see guys, this Falcon model doesn't have any embedding model. That's why I need to use Hugging Face embedding. And this is the model I'll be using for my embedding. Basically, I need to convert my text chunks to vector embedding. So that's why I need this one. Now I'm initializing my LLM, and I'm also initializing my embedding model. So see guys, it is first of all downloading the embedding model. Done. Now I will initialize my ChromaDB database, and I already showed you like how to initialize ChromaDB database in my vector database session. Just go ahead and check it out. So here is the DB name I'm giving, and I'm also passing my text entire corpus, okay, and I'm also giving my embedding. This is the embedding model, as you can see. So it should be embedding model. So this is the name. And I'm also giving my directory, like this is my DB directory. Now let me store the data in my ChromaDB. So it will convert all the text to vector embeddings, and it will store inside your ChromaDB. Now it has done. Now first of all, I will load this. So using this code, actually will load this uh, vector embeddings, okay. So this code will load the vector embeddings. Let me load. So it should be hf is my embedding. Then here I'm initializing this retriever as my vector DB. Then I'm creating one QHN, retrieval QHN. And here I'm giving my LLM. Now this is the process function I have just written. So whatever response I will get from my LLM, so it will process the output and it will give me that one. Now let me initialize the QHN. Now if you give any kinds of query and execute this code, you will able to see the response, okay. As you can see, you will able to see the response. I think I already showed you like how to do it, okay. So that's how we can use this Falcon 7b model, okay, with our custom task as well. Like we can create this kinds of generative AI application. Now guys, I want to give one particular task to everyone. Basically, see, you have learned lots of concept right now in the field of generative AI, like how to use this kinds of open source LLM model. Now I have already shown you like three very powerful open source large language model. Now one thing actually you can explore from your side, there is another large language model called Mistral 7b. So this is another very good model, and this is the website of Mistral 7b, and this model is also available inside Hugging Face. So Mistral 7b Hugging Face. So this is the model guys, Mistral 7b version 001. So this model you can load inside your free Google Colab. There is no issue with that. So you can follow the same technique to load the model, and you can perform these kinds of job here. And also try to share this notebook in the comment section. I will happy to see that, like whatever you have done from your side. So it would be pretty much good learning for you, right? So yes guys, this is all about our open source large language model. We have seen like how we can use them and how we can create generative AI application on top of it. Now in the next video, what I will show you, I will create one end-to-end generative AI projects, okay, with the help of this LangChain, then vector database, and these kinds of LLM. I will be also using a Streamlit package to create the web app and all. So guys, this is going to be very much interesting project. Just try to watch that particular video, then everything would be cleared. Like as of now, we have done the projects in the Google Colab, but now we'll be converting that Google Colab to like end-to-end projects. We'll be creating app and all.
I think you have heard of RAG inside generative AI, right? Because this is the most used actually topic inside generative AI. So the full form of RAG is like retrieval augmented generation. So in this video, we'll try to understand what is RAG exactly and how RAG works and why RAG is so important. Okay, let's say whenever we'll be working with generative AI, whenever we'll be implementing any kinds of, let's say, application. So why we have to follow this RAG concept there. Fine. So guys, I think you already know inside generative AI, we use something called large language model. That means LLMs. So LLMs actually have some limitation. You can see the first limitation it is having. So the first limitation you can see, LLM can't answer correctly to the private data. Let's see if we're having any kinds of private data. So that large language model won't be able to give you the answer related that. So if I give you one example, let's say you are having one personal website. Let's say I have one website called Code Commander. Okay, so Code Commander is my website. Now, if you open up your ChatGPT and if you ask related Code Commander, your ChatGPT won't be able to give the answer because ChatGPT trained with older data. That means I think ChatGPT trained around 2021 to 2022 data. Okay, around this year actually they trained this model. After that, actually I created this channel. Okay, so this data is not available inside my ChatGPT knowledge base. That means that time actually this data was not available in the internet. Okay, so you can consider it's a private data. Or you can consider any kinds of private data, your private, let's say, website data, private, let's say, your company data, anything. So if you ask any question related to the private data, your model won't be giving you any kinds of response to that, right? Then you can see the second limitation, LLM can't provide the most current information. Let's say if you're asking any question which is like more current, okay, more current, let's say, information, your model won't be giving you the answer. Let's say if you ask the question related this Olympic, okay, the current Olympic, it won't be able to give the answer because it hasn't trained with the current information. Okay, so these are the actually limitation we're having with the LLMs. But I want to create an application. That application will be also able to give the answer related to the private data as well as the current information. So how it can be performed? Okay, we can do it with the help of RAG concept. That means retrieval augmented generation. Now let's see how RAG works. So guys, here you can see RAG allows LLMs to use external sources for the better response. That means let's see if you're having any private data, let's say any external documents. So what you can do, you can give that documents to the large language model. How? For this, you just need to use one embedding model. You just need to use one embedding model. With the help of this embedding model, you'll just try to generate the vector embedding of the data. The data actually will be giving. And this vector embedding you will be storing to the knowledge base. That means to the vector database. Okay. I think we have already learned this thing previously. Previously, we already implemented this kinds of application. But I think you didn't know. Okay, this is a RAG application. I just given some high level overview, like how we can, let's say, use our external documents. I think we already created some of the project, right? So yes, this is called actually RAG. That means we are using our external documents. We are creating our knowledge base, and to the knowledge base, actually, we are integrating our large language model. Okay. Now, whenever user is asking any kinds of question, okay, whenever user is asking any kind of question to the private data, what it will do, it will go to the knowledge base. Okay, it will go to the knowledge base. Knowledge base will give the response. Okay, the question you are asking, the relevant question you are asking, and your LLM will process that answer as well as the query, and it will give you the correct response. Okay, so this is the complete architecture of RAG. That means retrieval augmented generation. Okay, so with the help of this concept, actually, we can easily use our private data sources or let's say external documents to get the information. Okay, I hope it is clear. That means if you are using RAG concept, it would be more accurate answer on the private data. Stay updated with the new information. Let's see if you're having new information, new data, what you can do, again, you can give that data to the knowledge base. That means you can use embedding model. You can convert those data to the embedding representation. You can store to the knowledge base and you can connect your large language model there. And if you're asking any question related that information, it will give you the answer. Okay, your model will give you the answer. So this is the concept of retrieval augmented generation or RAG. So guys, now let's try to see how RAG works. So as I already told you, whenever you are using RAG, that means you are connecting your external data. That means your private data. Let's say you have connected your private data. Let's say you have connected your website. Okay, you have connected your website. That means from the website itself, it will extract all the information. Let's say you are running one e-commerce site. So user has asked one question, what are your business hours? Okay, Now, how it will give the response by using your information. So first of all, what it will do, it will try to use something called retriever. So with the help of retriever, it will try to fetch all the information from your website. Okay, all the information it will fetch from the website itself. Then it will perform something called augmentation. So what augmentation will do, it will just try to augment the query. That means whatever question user has asked, okay, and the data actually you are getting after retriever, so it would be actually augmented. That means it will add them together. Okay, let's say the query as well as the data. Then it will pass to the generation. That means to the large language model. Large language model will try to understand the entire data as well as the query user has asked. Okay, and based on that, actually it will provide the answer. So the answer is Monday to Friday from 9:30 a.m. to 6:30 p.m. Okay, so that's how actually RAG works. That means it will use actually three components. One is like retrieval, another is like augmentation, another is like generation. Okay, that is why it is called retrieval augmented generation. Okay, I hope it is clear now. So guys, this was the introduction of the RAG, and I think you got it, how RAG works and all, and why RAG is important. Now let's try to see one practical example of RAG. So guys, here you can see I already prepared one code example of the RAG demo. So first of all, we'll try to understand this Jupyter notebook file. Then I will also show you how we can create a user application. That means app, let's say Streamlit app, how we can create it. Okay, so for this, what you have to do, guys, first of all, you have to install. These are the requirements, and this code would be shared, guys, in the resources section. From there you can download. And I already told you how to create a virtual environment. So to create the virtual environment, you have to execute this command. So conda create -n. You have to give the name. Let's say here I have given OpenAI demo. You can give any kinds of name. Let's say I will give test, then Python is equal to 3.10. Okay, 3.10, then -y. So this is the command you have to execute, and make sure you are using Python 3.10. Okay, so for me, I already created. I'm not going to create again. Then after that, you have to activate it. That means conda activate your environment name. Okay, then you have to install this requirements. Just write pip install. Okay, -r requirement.txt. Fine. Now if I see press enter, it will install all the requirements I'm having in the requirements file. Now you can see inside requirements file, I'm installing LangChain community, LangChain OpenAI, python.env, Streamlit. Okay, so these are the actually dependency package you have to install one by one. So for me, I already installed each and everything, you can see. Then after that, just open this notebook, RAG demo notebook, and try to select the environment. So let's say I have created this environment, OpenAI demo, I'll select it. Now see, now if I execute the first line, see, it is working fine. There is no error. Okay, that means it is working fine. So guys, in this experiment, I'm going to use one website. Okay, that means as a private data, as a, let's say, external data, we'll be using website. So from the website itself, we'll be collecting the data. On top of that, actually, we'll be implementing this RAG application. So you can see this is the website URL. Now let me open this URL. So this is the URL of the website. So this is the entire website, guys. You can see. So they have given different information. So now I just collected some of the more page. Let me show you. So this is another page. This is the index page, and this is the contact page. Okay, now let me open them. See, this is the index page, this is the contact page. So you can see, guys, this is the index one and this is the contact one. Okay, so that's how actually you can use any kinds of website. I'm using this website. For you, you can use your, let's say, personal website. You can use your, let's say, private website, your official website, anything you can use. Even I will also show you how we can use any other format. Let's say how we can use PDF documents. Okay, these are the things I will also tell you. So this is the website data actually I'll be using. Now to load this website, I'll be using something called unstructured URL loader, and this is available inside LangChain. Okay, you can see I'm importing this unstructured URL loader. Now this is the URL list. So if you're having multiple URL, you can create a list, and this list you can pass to this function, and this function will give you one loader object. Now you can call loader.load, and it will extract the data. Let me show you. So if I execute this line, now see, it is extracting all the information from the website itself. So extraction is done. Now if I show you the data, now you can see it has extracted all the information. Now why 3 documents is coming? Because here I was using 3 URL. Okay, 3 different I actually pages. Okay, that's why it is coming 3 documents. Okay, now what I have to do, guys, I think you remember we have to perform something called chunking operation. So for this we can use recursive character text splitter. Either we can use character text splitter, either you can also use token text splitter. Okay, so here I'm using recursive character text splitter. So here chunk size is equal to, I have given 1000. That means 1000 word would be considered as my 1 chunks. So let me create the chunks and let me show you the chunks size. Okay, you can see 11 chunks it has created. Okay, now if you want to see the first one, so you can see this is the first chunks, and this is the URL it is referring. Now I think you remember, after extracting your data, that means documents, you have to use one embedding model, and you have to generate vector embedding, and that vector embedding will be stored into the vector database. Okay, any kinds of vector database you can use. So I have already showed you like multiple vector database. Like we can use ChromaDB, Pinecone, Weaviate, okay, Files. You can use any of the vector database. So here I'm going to use something called ChromaDB vector database. Okay, ChromaDB is a local vector database. Fine. So guys, you can see I'm importing Chroma from the Langchain itself, because inside Langchain this ChromaDB is available. Then I'm importing one embedding model. So here I'm using OpenAI embedding model. Okay, OpenAI embedding model. You can also use any open source embedding model. I'll also tell you okay how we can do it. Then I'm also importing OpenAI. That means I'm going to use OpenAI large language model. So let me import all of the package. And now if I want to use OpenAI, what I have to do, I have to set my environment. Okay, environment variable. So OpenAI API key, you have to pass your API key. So just try to create one API key and try to pass here. Then let's load this API key with the help of load env package. Then after that, I'm going to initialize my ChromaDB vector database. Okay, so you can see I'm going to pass my documents here, the documents I'm getting. Even I'm also passing my embedding model. So it will give me the vector store, entire vector store. That means this is going to be my knowledge base. Okay, see, this is my knowledge base right now. Now here you can perform something called semantic search operation. Okay, similarity search operation. So let me show you one example. So vector store as retriever. I want to perform similarity search operation. Search keywords, that means how many, let's say, result it will return. So here I've given 3. That means after searching, it will give me 3 relevant answer. Okay, let me show you. So let me create the retriever object. Now here I'm asking one question, what kinds of service they provide. Okay, this website, let's say I'm asking one question. Now if I perform the invoke operation, see, it will give you 3 results. Okay, 3 results actually it will give you. So let me show you. See, it has given you 3 relevant information, and from where it is referring, it has also given the URL, and you can see the 3 relevant information. But what I need the actual response. Okay, this question I have asked what kinds of service they provide. I need the actual response. I don't need this kinds of response. Okay, for this what I have to do, I have to connect my large language model. I think you remember. So here I have to connect my large language model. Okay, then user will ask the query. So it will process the query as well as the relevant, let's say, answer will be getting from the vector database. Then your LLM will give the actual response. Okay, so now let's try to see how we can perform it. Now, if you want to see the page content, okay, the let's say result you are getting, if you want to see the contents, what you can do, you can call this one page content. Okay, I want to see the first, let's say, answer page content. So this is the entire page content. You can see. Fine. Now here I'm initializing my large language model. I think you know what is temperature parameter, what is max token parameter. Now here you can see I have created one chain. Okay, create retrieval chain. So this will give me the chain object. That means I can connect my large language model as well as the vector database. Okay, then I'm also going to pass one prompt. Okay, system prompt, and for this I'm going to use prompt template. Okay, I think you remember we can also create the prompt template. So this is the prompt I have created, guys. You can see you are an assistant for the question answering task. Use the following piece of retrieved context to answer the question. If you don't know the answer, say that you don't know, use 3 sentence maximum to keep the answer concise. You can also change the prompt, it's up to you, but I will use this prompt. Okay, it will take the context and it will give you the answer. Now for this I'm going to create a prompt template first of all. So here I've created the prompt template. This is going to be my system prompt, and user will give the input. Okay, whatever input actually user will ask, let's say this is the input user will ask. Okay, this input actually it will come here. Okay, and it will create the complete prompt that time. Now let me initialize the prompt. Now here I'm going to create a chain. So I'm using create stop document chain. So this is the function actually I'm using, because I already told you inside Langchain actually we are having different chains, right? Now here I'm passing my LLM as well as the prompt. Then again, what you have to do, you have to call another function create retrieval chain. Okay, so inside that you have to give your vector database. Okay, the vector database you have created, that means your knowledge base, and you have to give this object, your question answer chain. Okay, this object actually you have to give. Now it will give you the entire RAG chain. Now here you can ask any kinds of questions. So here I am calling this RAG chain invoke, and this is the input, what kinds of service they provide. And I'm only extracting the answer. Now see, if I show you the answer right now, see, this should be the concise answer. That means the accurate answer actually it will try to provide. Now see, Victoria on Move provides efficient and careful relocation services for the apartment, village, householders. Okay, see, blah blah blah. That means it is giving me the correct information right now. Okay, so this is called actually RAG system. Now it is referring my private data, my external data. On top of that, actually it is giving me the answer. And if you ask this question to the ChatGPT won't be able to give the answer, because ChatGPT hasn't trained with this data. Okay, I think you are getting my point. Now let's try to see how we can create a user app. Okay, so what I've done, I've created another file called app.py, and whatever code I have written, okay, cell by cell, I just copy pasted and I just created like that. In this particular dot file, you can see I've imported all the library. I'm loading my, let's say, secret keys, that means OpenAI API keys. Then I'm giving the URL, I'm extracting the data, I'm creating that means chunks. Okay, then I'm creating the vector store. I'm initializing my large language model. Then I'm using Streamlit. You can see st, then I'm initializing my prompt. So you can see this is the prompt. And now if user is asking any query, this query actually I'm passing here and it is giving me the response. That response actually I'm showing on the Streamlit application. Okay, now let me execute and let me show you how this app will look like. So for this, you can execute one command called Streamlit run app.py. Okay, now see if I execute the command, so it will open up my application. Now see, this is the title. I think you saw that st.title we have written here. See, RAG demo. And this title will show in the search bar. You can see this is the search bar because here I'm taking chat input na. So you can see this is the chat input. Here it will show the message. Now you can change the message as per your requirement. Now let me ask one query. So I'll ask the same query. So I'll copy this query. And here I can ask. You can go to the website and you can ask any kinds of query. It's up to you. So guys, as you can see, it has given me the response. Victorian Move provides range of services including apartment moving, villa moving, okay, and so on. That means it is working fine right now. You can ask any kinds of question, guys. Any kinds of question you can ask, whatever actually information you are having in this website. Fine. So yes, guys, this is the RAG demo, and that's how we can create a RAG. Going forward, we'll be also learning some advanced RAG. We'll be, let's say, creating hybrid RAG and all. Okay, going forward, we'll be learning. These are some advanced RAG application you can also create. So in the next video, what we'll do, we'll just try to create another RAG application, okay, with the help of a Google Gemini Pro model. Okay, this is the open source model we'll be using. With the help of that, we can also create a RAG application. In this video, we'll try to understand what is the difference between RAG versus fine tuning. Because many people has this question, when we have to perform the RAG, when we have to perform the fine tuning operation, and what is the difference between them. So see, both technique actually we use to extend the abilities of the large language model. Okay, see, when you have to use the fine-tune approach, when you have to use the RAG approach, let's say you are working in a very specific domain with some specific data, okay, and with some specific task, that time actually you can use something called fine-tune approach, because whatever pre-trained large language model you will be using, it won't be having like these are the information. Let's say you are working in the field of medical, okay, medical domain, and there actually you are creating one bot, okay, you are creating one medical, let's say, information bot. So this will give you, let's say, medical related information. And here you are using very specific data. Okay, so this data actually was not used during training of this large language model. So that time, what you can do at the very first time, you can do the fine tune operation. That means you can fine tune one pre-trained model and you can create this application. So let's say this is the application we created. Now user has given one question. What are the latest treatment for the type 2 diabetics? So whenever you train this model, so you provided actually these are the information. So the latest treatment for the type 2 diabetics include meditation like metformin, then lifestyle changes such as diet, exercise, and in some cases actually insulin therapy. So these are the information actually you have given during fine tune. These are the model. Now let's say there is a new treatment came. Now if you are asking the same question again to your, let's say, system, it will give you the same answer again and again because it is already trained with your older data. Yes or no? So that new information actually it doesn't have, so it won't be able to give the new actually, let's say, technique for the, let's say, treatment of diabetics too. Now in case what you can do, you can use this new information and you can create a RAG based application. So what you have to do, you have to use the same LLM model only, but you will be creating one additional knowledge base. I think I showed you how to create the RAG. So with the help of this data, you'll be creating one additional knowledge base, and with that knowledge base, you will be connecting your medical bot. Then your medical bot will be able to give the response, okay, from the latest, let's say, technique, from the latest information. Yes or no? Okay, now I think you got it. When we have to use the RAG technique, when we have to use the fine-tuning technique. Now see, here we are using RAG technique. Now if you are asking the same question, now here you will see that it will give you the recent treatment, okay, for the type 2 diabetics. Okay, the recent treatment, whatever actually it's came in the market. Okay. Now I think this is clear when we have to use the fine-tuning technique, when we have to use the RAG-based technique. And again, fine-tuning is like more costly. So for this, you need huge amount of data. You need a good computational machine. That means you should have GPU, good configuration RAM. Okay. If you're not having this kinds of GPU, so you can't do the fine-tuning operation. That means in fine-tuning, you are retraining that model. You are updating the weights, right? Which is not involved inside RAG. So inside RAG, actually, we are not training any kinds of model. Instead of that, we are creating an additional knowledge base. And with the knowledge base, actually, we are connecting our large language model. Okay, this is the difference only. Fine. Now, I think, guys, you got the clear-cut idea. What is the difference between RAG versus fine-tuning and when we have to use it. So even I will also show you how we can perform the fine-tuning operation. Okay, let's say if I want to create any specific task, how we can perform the fine-tuning operation out of our custom data. So guys, as of now, we have seen the RAG demo. Like I already showed you what is RAG and what is the use of RAG and why we have to use the RAG. Okay, even I also showed you what is the difference between RAG and fine tuning. So in this video, we'll be implementing one RAG based project. So the project name is QA system. Okay, we'll be using here Gemini Pro model and Langchain. So if you don't know, Gemini is a large language model developed by Google. Okay, so we'll be using this model. And this model is actually free, so we can use actually Google API to use this model. Okay, I'll tell you how we can collect the API key, and with the help of that, how we can use this large language model. Now see, this is the entire diagram of our project. That means here we'll be creating this RAG application. So we are having some external documents. So in this case, actually, I'm going to use PDF documents. I'm having some PDF documents. Okay, we'll be using this data. So we'll be first of all extracting the documents. Then after that, we'll be performing the chunking operation. Then we'll be building one semantic index. Okay, that means we'll be creating one knowledge base. That means whatever, let's say, data we'll be getting, we'll be trying to using embedding model to generate the vector embedding. Then we'll be storing this vector embedding to the vector database. Then user will ask some query. This query will go to the knowledge base. Knowledge base will return some of the relevant answer. And with the help of large language model, we'll just try to process the answer as well as the question. And it will give you the correct answer. Okay, so this is what actually we'll be implementing here. So let me show you how we can develop this particular application. So I already prepared one example. So let's open up. So guys, as you can see, this is the demo. So for this, what you have to do, again, you have to create one virtual environment. I already showed you how to create the virtual environment. For this, you can use this command conda create -n, give the environment name, then specify the Python version, let's say 3.10, then -y. Okay, this is the command to create the virtual environment. After that, just try to activate with the help of conda activate command, then install the requirements. So pip install -r requirement.txt. So for me, it is already installed. See, that's why it is telling requirement is already satisfied. So let me show you the requirements. So these are the requirements you have to install, guys. So same requirements only as per our previous project. The only thing I have added is Langchain Google Gen AI. So with the help of this package, actually we'll be accessing the Gemini model. Okay. So here vector database wise, I'm going to use ChromaDB again. You can also use Fias, Pinecone, okay, Weaviate, any kinds of vector DB you can use here. So let me open this first of all notebook and let me explain, okay, what are the things we'll be doing here. So guys, you can see I'm having one PDF document. Let me show you this PDF. So this is the PDF, guys. So this is my research paper actually. So I published this research paper. So you can see I'm the author here. So I'm the author here. And the research paper is about development of multiple combined regression method for rainfall measurement. Okay, now you can read the paper. Like what are the things actually we have proposed here. So we'll be asking some question, okay, from this paper itself. That means this is my private data, this is my external data. On top of this data, actually I'll be performing the chat operation. So here I'll be asking some questions related this particular data. Okay, now let me show you how we can do it. For this, first of all, we have to load the PDF. For this, we can use PyPDF loader from the Langchain. Now let me load the data. So it will, you have to give the path of your, let's say, data. So here is my path, my pdf.pdf. Now see, it will give you enter extracted documents. That means you can see it is having around 15 pages. Okay, 15 pages in the research paper if you open it up. Then what you have to do, you have to perform the chunking, guys. I think you know what is chunking. So here chunk size is equal to, I have given 1000. That means 1000 what would be considered as my 1 chunks. Now see, if I execute, here I will get around 44 chunks. Okay, now if I want to show you, so this is my first document chunks. Now I have to get the Google API key. So for this, you can open this link. So this is available inside Google AI Studio. So just click here, Google AI Studio. Now from here, you have to collect one API key. Now see, it will give you this kinds of interface. Now you can create an API key. For me, I already created. I won't be creating again, but for you, you can create here. See, just select the project. If you don't have project, just try to create a project and try to create the API keys. Now see, if I click here, create API key in existing project, it will create the API key. Okay. Now after creating the API key, you will get this kinds of API key. Okay, this is your Google API key. Now just try to give the key Google_API key is equal to paste your key here. Make sure you are writing like that, otherwise it won't be working. Fine. Now let me save. Now if I open up my notebook. Now guys, what I have to do, I think remember we have to use one embedding model. Okay, embedding model just to convert my data to the vector embedding. Now for this, we'll be using one open source embedding model from the Google. So you can see this is the embedding model, embedding 001. And this is available inside this Google Generative AI embedding. Okay. Now apart from that, you are having so many embedding model. Let me show you. Let me open this link. So you can see you are having AI2, AI Labs, then Aleph Alpha. Okay, so these are the actually provided. So it is also having different embedding model. You can use them as well. So let me load this embedding. For this, I'm going to import this library. I'm going to load the API key. Then after that, I'm loading this embedding model, you can see. Then after loading the embedding, I'm just doing one test operation. I'm just writing hello world, so it should give me the vector representation. Let me show you. So this hello world is represented with this vector, and I'm only printing 5 actually vector. You can also print the complete vector. Okay, now let me create the knowledge base. For this, I'm going to use ChromaDB. I already told you. Inside that, I'm going to pass my documents as well as the embedding model. You can see embedding model. Now it will give me the knowledge base. Then again, I can perform similarity search operation, that means semantic search operation. For this, you can execute this line of code. So it will give me actually 10 relevant answer. And this is the question I'm asking: what is the new in development of multiple combined regression methods in rainfall measurement paper? So this is my question. Now see if I execute, it will give me 10 different response. Now if I want to show you, so 10 different relevant response actually it will give me. Now if you want to see the page content, you can also see that. See, this is the page content. Okay, now I will be integrating my large language model. So for this, let's initialize my Gemini model. You can see, so here you can see I'm initializing my Gemini model. For this, I'm using Chat Google Generative AI. Inside that, you have to give the model name Gemini 1.5 Pro. This is the model. So Gemini having different model. You can search Gemini model list, you will get different model list. So from there, actually I'm using 1.5 Pro model. And temperature max token parameter, I think you already know. Okay, I already explained this part. Now again, I have to create the chain. I think you remember the same chain actually we are creating. The same we have created our previous project as well. After that, we are preparing the prompt. Okay, this is the same prompt I'm using. This is my prompt template right now. So let me execute. Then here I'm creating the complete chain. I'm giving my LLM object as well as the prompt. And this one I'm passing to my create retrieval chain. Okay, you can see I'm giving my vector database as well as my this object. Now this will give me the complete chain. Now here I'm asking the question again. The same question: what is the new development of multiple combined regression methods for the rainfall measurement paper? Now see if I ask the question, it should give me the answer from the paper. So guys, here you can see I got the response. The paper of development multiple combined regression methods for rainfall measurement introduced a novel approach to predicting rainfall quantity. The author utilized 10 supervised regression machine learning models to predict the rainfall based on the historical weather data. Their goal is to identify the most accurate regression techniques for the rainfall prediction. See, it is giving me the correct response. Now if you see the paper, if you read the paper, you will see that we have proposed the same thing here. That means it is working fine. Okay, that's how also you can use different data sources. That means if you're having any private data, okay, if you're having any custom data, you can create the RAG based application like that. So guys, this was the notebook experiment. Now let me show you how we can create a user app. So for this, I'm going to again use Streamlit, and whatever code I have written here, I just copy pasted inside this app.py. You can see all the import operation. I'm loading then my secret key. That means my Google API key. Okay, here I'm loading it. Then I'm loading my documents, performing the chunking operation, creating the vector store, initializing the large language model. This is my prompt, and this is the chat input I'm taking. That means I'm creating one chat input box with the help of Streamlit. So this is my prompt. Then after that, if user has given any query, so it will do the generation, and it will show the on top of my Streamlit application. Now let me show you how it will work. So for this, you can run this command: Streamlit run app.py. So guys, you can see this is the title: RAG application using Gemini Pro. You can also change it here. Okay, anything you can give here. Now here I got the input box. Now I can ask any question. Let's say I will ask the same question. You can ask any question from my paper. Just go to the paper and ask any kinds of question. So here we're using Gemini model through the API request, and it is like free API. Okay, you don't need to pay for anything. Now see guys, this is the answer I got. Now if you see the answer, it's pretty good. Okay, that means the correct information it has given me. So yes guys, this is the project actually, the QA project we have developed with the help of Gemini Pro, Langchain, and vector database. So far we have learned about like RAG, retrieval augmented generation, and there I showed you what is the use of RAG and how we can create a RAG. Okay, even I already I think discussed what is the difference between RAG versus fine tuning. That means if you want to work in a domain which is like completely new domain and you are working with very specific task, that time what you can do, instead of implementing the RAG, you can fine tune one LLM. Okay, and to fine tune the LLM, what you have to do guys, you have to use one pretrain model. On top of pretrain model, you have to train your custom data. So let me open up my Blackboard and let me discuss there what is fine tuning exactly. So guys, inside fine tuning, you will be using one pretrain model. Okay, pretrain large language model. Okay, I think I already showed you there are so many large language models are available as open source. For this, you can go to the Hugging Face. So here you can see there are thousands of large language models are available. Now you can choose any kinds of model as per your requirement. Let's say you want to use something called Llama, Meta Llama. You can simply search Llama here. So you will get see all the Llama model. Okay, Llama 2, Llama 3, all kinds of model actually will see that. See, okay, and this one Meta AI. Now what you can do, you can download this model. On top of that, you can fine tune your custom data. But before fine tuning, what you can do, see, first of all, let's say whatever, let's say project you want to implement. Let's say you want to implement one chatbot. Let's say you want to implement one medical chatbot. Okay, medical chatbot. First of all, use one pre-trained large language model and try to perform the inference operation. Okay, try to perform the inference operation, inference on top of the model. If this model is able to give the correct answer, okay, if it is able to give the correct answer, try to select this model. Okay, otherwise what you can do, just try to build one RAG, retrieval augmented generation. Okay, that means create a external knowledge base, then try to connect your one pre-trained large language model and try to again perform the inference operation. Okay, and try to see the accuracy of the model. Try to see like whether your model is giving able to give the correct response or not. If it is giving, try to select this model. Okay, otherwise if this both approach is not working, that time what you can do, you can perform the fine-tuning operation. Okay, fine-tuning operation. So there what you can do, you can take one pre-trained large language model from Hugging Face, from any kinds of, let's say, platform, and on top of that you can train your custom data, the data set you are using. Let's say you are using one very specific medical, okay, medical data. That time you can use this data and you can train one custom model on top of it. Okay, this is called actually fine-tuning, and that should be my suggestion, guys. I mean, directly don't do the fine-tuning. Before that, try to check whether pre-trained model is working or not. If pre-trained is not working, try to build the RAG based system. If it is not working, then try to do the fine-tuning. Okay, because fine-tuning is a more costly task at the end, because here you need like huge amount of data, even you need lots of computational power. You need actually higher configuration machine. Okay, you should have good GPU instance in your system, otherwise you can't do the fine-tuning operation. But if you want to do the fine-tuning operation, there is some way actually we can do it, because all kinds of large language model you can see, it is having actually huge parameter size. You can see Llama 2 7B, that means it is having 7 billion parameter. It is having 8 billion parameter. That's how it is having 70 billion parameter. Just try to consider. Okay, it's a huge size model. So we can't use any kinds of low configuration machine here to fine tune these are the model. So for this, what we can do, we can use something called PFT technique. We can use something called PEFT. Okay, what is the full form of PFT? Parameter efficient fine tuning. Okay, this is the full form of PFT. So inside this PFT, we are having some method we can use. So the first one, you can use something called LoRA, or you can use something called QLoRA. Okay, so this LoRA and QLoRA will help you to do to perform this parameter efficient fine tuning. That means it applies something called quantization technique. Okay, that means it will load your model in a lower memory instance. That means it will load your model in a 4-bit precision, 8-bit precision. Okay, that's how actually it will perform the parameter efficient fine tuning process. Now you can ask me, what is quantization then? Okay, let me show you what is quantization. See, quantization is nothing but it's just a way of converting from higher memory format to a lower memory format. So this is called actually quantization. Now I think you already know about neural network, right? Let's say this is one neural network I'm having. So inside neural network, what do we have? We have lots of weights, yes or no, right? We have W1, W2, okay, and W3 and so on. So this is what actually we are having. That means we are having lots of weight and biases. Let's say B1, B2, and so on, right? Now you can represent these are the weight as a matrix, because if you know about artificial neural networks, so there I think you know how we can represent, these are the weights, okay, how we can represent our input data and all. Okay, let's say this is the one 3x3 matrix I'm having, and inside that we're having lots of weights. Let's say w1, w2, w3 and so on. Okay, this is the weights, and this weight is nothing but it's a floating number. Okay, it's a floating number, it's a floating value. If you see any kinds of weight, it would be like that, let's say 7.23000 like that. Okay, so this is called actually floating value. These are the floating value, and if you see, this floating value stores in a FP32 bit. Okay, FP32 bits. Now what is the full form of FP? FP means full precision. Okay, full precision. Okay, full precision, you can also call it as single precision. Okay, single precision. Got it? So whenever we are doing the quantization, that means what we are doing, we're just trying to convert this higher memory representation to lower memory representation. That means it is now saving these are the weights in the FP32 bits. Now what we will be doing after doing the quantization, we'll be converting this 32 bits to, let's say, 8 bits. Okay, 8 bits, or let's say 4 bits. 4 bits. That means what will happen? Let's say you are having one floating number like that. Let's say 1.70890. Now, if you want to convert it to 8 bits, what you will be doing? You will just remove, these are the numbers actually. These are the numbers actually you will remove. And you will take this number only. So that's how actually you can reduce the memory size. That means you can convert any kinds of higher memory actually format to lower memory format. So this is called actually quantization. Okay, I hope it is clear. And the technique actually we usually use, let's say LoRA and QLoRA. Okay, QLoRA. So these techniques help us to perform this quantization. That means it will load the original model as a quantized model. That means in a lower precision. Okay, let's say I want to load this model in a 4-bit precision. 4-bit precision. Okay, so let's say previously this model was in 32 bits precision, but I want to load in 4-bit precision. So how it will happen? With the help of QLoRA or LoRA, you can do it. Sorry, with the help of LoRA and QLoRA, you can perform it. We are having already some Python libraries. Okay, so we are having one library called PEFT. Okay, this is called parameter efficient fine tuning. So with the help of that, you can perform LoRA and QLoRA technique. So with the help of that, you can load any kinds of actual model. So these are the model. Okay, in a 4-bit precision, in a 8-bit precision. Okay, that means you can load as a quantized model so that you can perform the fine tuning operation. Because as I already told you, this actual model you can't load because it is having huge amount of size, huge amount of, let's say, weight size. Okay, and it is storing those are the weights in a 32-bit precision. And to load these are the model, we need a good configuration machine, good configuration GPU, memory, and so on. But we don't have that much of resources. We are having, let's say, Google Colab, free Google Colab, or let's say you are having a 3060 GPU. That time what you can do? That time you have to load these are the model. With the help of this, these are the technique actually. The technique actually I showed you. This one, quantization. That means you will be using LoRA and QLoRA. With the help of that, you will be loading the model and will perform the fine tuning operation. Now you can ask me, sir, if I'm doing that one, so definitely I will lose some information. Definitely will lose some information because you are loading the model in a 8-bit and 4-bit precision from the 32 bits. That means here you are getting rid of some of the numbers. So definitely you are losing some information. But again, LoRA and QLoRA takes care of this part actually. So they try to optimize your, let's say, model weights as much they can. Okay, so you don't need to worry about if you're using these at the library, everything would be happen in an optimized way. So we'll be learning as a practical also how we can fine tune one large language model. So in the next video, we'll be learning how we can fine tune one model called Llama 2, Meta Llama 2. Okay, we'll be fine tuning this model on top of our custom data. And here we'll be using this PFT technique, parameter efficient fine tuning technique. Got it? Because I'll be using free Colab here. If you want to do in your local machine, if you are having, let's say, any basic GPU, you can also do it. But I'll try to train on Google Colab if you're not having any kinds of GPU, okay, and not having any kinds of good configuration machine, you can perform on Google Colab. Fine. So yes, guys, this is the introduction of fine tuning, and I think you got to know how we can perform the fine tuning operation and what is this PFT, okay, PFT technique exactly, and what is LoRA and QLoRA, because I know that many people will have this question: what is QLoRA, LoRA, and what is PFT and all. Okay, so I think now everything is clear. Okay, how things are working here. Fine. So in the next video, we'll see the practical demo of the fine tuning. So we'll be fine tuning one model, large language model called Meta Llama 2. So here we'll be fine tuning one large language model called Meta Llama 2. I think you know Llama 2, right? Llama 2 is a large language model. So if you go to the Hugging Face and if you search for Meta, Meta is having different large language model. If I show you, let's say if I go to the Meta LLM, see, it is having different large language model like Meta Llama 3.1, Llama 2 is also there. If I expand all the things, see, this is the Llama 3 family, this is the Llama 2 family. So the way actually I'm doing the, let's say, fine tuning of Llama 2 family, you can also perform Llama 3 as well. Why I'm taking Llama 2? Because it would be a little bit, small size model. That's why I'm taking Llama 2. You can also take Llama 3 as well. Okay, the process will remain same. And how to get the permission from the Llama, I think I already showed you in my open source large language model session. So you have to apply for the permission first of all, and they will give the permission. Then after that, you can load it. And if you're not getting the permission as of now, what you can do, I can also show you one alternative approach. You can also follow this one. Fine. I think I already showed you one alternative approach, like you can use any other repository to load the model. It is also fine. Then what you can do after fine tuning this model, you can also push this model to the Hugging Face hub. Let's say if I show you my hub now, so if I go to my profile, see, I already published one model, this fine tune Llama model. After fine tuning it, I publish this model in my Hugging Face hub. Now people can use my model. So they will be just copying this name and they can use my model. You can see it is already downloaded 65 times. Okay, 65 times this model got downloaded by the audience, right? So that's how actually you can also publish your model. If you want, you can also publish your model to the Hugging Face hub. Got it? So that people can also use your model. Got it? So now let me show you how we can perform the fine tuning. For this, I have prepared one beautiful notebook. So in this notebook, actually, I have written each and every step you want to follow. So first of all, make sure you selected runtime as GPU because you are doing the fine tuning operation and definitely you need a GPU. So I'll be selecting T4 GPU because here I'm using free Google Colab. You can also take the premium subscription of the Google Colab. If you're taking the premium one, so you'll see that your training would be a little bit faster than this free one. Fine. Now let me connect this notebook. So guys, as you can see, my notebook is connected. Now the first thing what you have to do, you have to install some of the required packages. So here I have listed down all the packages actually you need, like let's say Accelerate, then PFT. PFT is the parameter efficient fine tuning that package. Accelerate you need if you're using transformer library, and if you want to, let's say, use the GPU, that time actually you need to install this Accelerate as well. Fine. Then you can see bits and bytes is also requirement of the transformer. And if you want to set up everything in your local machine, that means if you're having local GPU, but if you don't know how to set up the GPU, no need to worry. I have created one dedicated video. Let me show you. So if you search my YouTube channel DS with Bappi, so here you will see that I have created one video in the video section, set up NVIDIA GPU for the deep learning. So here I showed you how we can install the CUDA and CUDA toolkit. So definitely, first of all, you have to set up your GPU in a proper way. Then you will be able to set up everything. That means you will be able to utilize your GPU. So make sure if you're doing local setup, you can try to watch this video. Okay. Otherwise, if you're doing on Google Colab, try to do the same thing the way actually I'm doing here. So let me install all the packages. So guys, as you can see, installation is completed. Now, the second thing, you have to import all the necessary library. So you can see I have imported all the necessary library like auto model for casual LLM, auto tokenizer. Okay, I think you already know these are the thing. The Hugging Face actually library. Okay, why we need it. Then you can see I'm importing something called PFT. That means parameter efficient fine tuning. So from PFT, I'm importing something called LoRA. You can also use QLoRA, but here I'm using LoRA. Okay, so both technique we can use. It's up to you. So let me import as of now. So whenever I will be using it, I'll tell you, okay, what are the packages actually you are using and for which task. So see guys, execution is completed. That means everything is working fine. Now, let me show you the data set first of all. See, this is the original data. So let me open the data. See, this is the original data. So the data set name is Open Assistant. So the data set name is Open Assistant Guanaso. I think this is the data set name. And you can see this is the data. That means it is having some conversation between human and assistant. You can see. So conversation between human and assistant. You can see human and assistant. So this is the human, let's say conversation. And this is the assistant conversation. Okay. So that's how actually they have collected this data. And it is having actually, you can see how many example. In the training, you are having 9.85k rows. Fine. Almost 10k example you are having. Now see, it is also using different languages. See, different language actually they have collected the data. Not only English, it is also they are using Chinese language also. They're using different language. That means it is a multi-language data and it is a conversation data. So we'll be training one chat model. That means Llama to chat model. Okay. I think I already showed you what is the difference between Llama to chat model and fine-tuned model. Let's say if you want to only perform the text generation, that time you can use pre-trained model. Okay. And if you want to perform, let's say, chat operation, and let's say all kinds of tasks, the way actually you perform with the ChatGPT, that time you can use chat model. Now, if you open the Hugging Face and if you go to the actually Llama model, you will see that it is having different model. Let me show you. So if I search for Llama, see if I go to the Llama 2 series actually, Llama 2 family, you can see it is having Llama 2 7B model, HF model, and it is also having something called chat model. You can see, chat model. Chat model means you can perform the conversation, chat operation, the way actually you perform with the ChatGPT, right? So we'll be fine tuning one chat model. So that is why I'm using this chat dataset, conversation dataset. Okay, instruction. So these are the instruction. I think this one, see, this is the instruction human is giving, assistant is replying. So these kinds of dataset actually will be using. Now you can use any kinds of data. You just try to prepare your data, okay, in that format. You can also create a CSV file. So inside CSV file, in first column, you can write the human, let's say, conversation. In second column, you can write the assistant conversation. That's how also you can collect the data. Okay, it can be any kinds of format. So as of now, we are using the data from the Hugging Face. You can also use your custom data. And how to upload your custom data to the Hugging Face? For this, you can see Hugging Face documentation. They will also give you the let's say entire process, like how I can, let's say, publish my data to the Hugging Face hub, and from there I can load my data. It is also possible. But most of the data actually we'll see from the Hugging Face itself. You can use it from there. So see, this is the Llama 2 supported data. That means whenever you will perform the fine tuning, so you have to convert this data in that format. See, this is the format. So first of all, you have to give the S token. You can see S token. Inside that, you have to give the instruction. And what is the instruction? Instruction is nothing but it's a human conversation. Whatever conversation human is doing, this is called instruction. See, if I open this example, see, this is the human. See, this is the human conversation. Okay, see, till this token actually, that means /inst, that means instruction. This is the human conversation. After that, whatever text you can see, this is the assistant conversation. Okay, this is the assistant conversation. Got it? So that's how actually you have to prepare your data. And at the last, your S token will end again. Okay, that means this is the complete system token right now. The complete prompt. That means you are creating the prompt here. Because my large language model supports prompting, right? So that means we are creating the prompt here. So that my model can understand whenever we are doing the inference, whenever we are, let's say, sending any kinds of prompt to the large language model, it can automatically understand. We are sending the prompt. Okay, so that's why I'm first of all teaching my model. This is instruction. And after instruction, whatever actually message you can see, this is the your output. That means your response, assistant response. Okay, this is the format. Now, if you open any kinds of data, you'll see that it is using the same format only. Okay, same format only. So we have to convert our data, this format to this format. Okay, now you can ask me how to convert this format to this format. For this, we can use one notebook. See, this is the notebook, guys. Even I already attached this notebook link inside this original notebook. Let me show you. See, this is the notebook. Okay, so in this notebook, actually, I already written one function transform conversion. So this one actually will take the human conversation as well as the assistant conversation and will add these at the token. Okay, like that, the way actually I showed you here. Okay, I think it is clear. Now you can use this function as it is, and you can convert any kinds of, let's say, these kinds of conversation data to your like LLM format. That means your Llama 2 format. Now there are so many large language model. It takes actually different kinds of format. If you go to the documentation of the Hugging Face, you will see that what kinds of format they supports. Based on that, actually you can actually write the converter. Also, you can get this converter from the Hugging Face itself. Hugging Face also provide these kinds of converter. You can use this converter to convert your data to a specific format. Okay, so most of the large language model will follow this format only. Okay, we'll see that most of the large language model will follow the same format. The format actually I'm using here. Fine. So that's why you can use this converter as it is. Now see, here I'm loading the data. That means my entire data. That means this data, this Open Assistant data. You can see I'm giving the name of the Open Assistant. Then see, instead of taking all the data, all the, let's say, 10K example, I'm only taking 1000. Okay, 1K actually example, because here I'm using free collab and fine tuning will take time. That's why I'm only taking 1000 example to perform the fine tuning operation. And I'm doing the, let's say, conversion operation. Then after that, I'm just pushing this, let's say, data here. So this is the data. Now see, the same data, but here actually this guy is taking actually 1K example, and he has already converted this data to the required format. Okay, so this is so this data is already available. You can see this guy has already converted this data to this format. So directly you can use this data. But if you want to do it, so this is the notebook you can use. Okay, the same notebook you can use. Got it? And if you want to use the entire data, guys, what you can do? So here I've already given the complete reform dataset link. You can open it up. So see, it is having actually 10k example only. See, around 9.85k rows. Now see, it is already formatted. Okay, it is already formatted. So you can also use this data. If you're using good configuration PC, you can use this data, okay, for the fine-tuning operation. But I'm going to use this data actually, 1k example data. Okay, only 1k example I'll be taking here. So guys, I think now you got to know how we can reformat our data for the Llama 2 model. And see, here we are using free collab, and free collab actually offers 15 GB of graphics card. If you see here, it will give you 15 GB of graphics card. See, okay, and here you will get disk around 112 GB, and RAM actually will get 12 GB. Okay, so this is the configuration of our free collab. Now here you can see it is having actually limit resources, barely enough to store Llama 2 7B words. That means we can only use 7 billion Llama 2 model. Okay, 7 billion Llama 2 model. If you're using 70 bay, 30 bay, 13 billion, that time actually will get difficulties. Okay, because it is a free Google Colab. But if you're using a premium Google Colab, that time actually you can also use this model. Okay, it's completely fine. Now here you can see full fine tuning is not possible. Here we need to perform the parameter efficient fine tuning technique, like we'll be using LoRA and QLoRA. Because the full model we can't load yet, we have to use a quantization technique. That means we'll be using LoRA and QLoRA to perform the parameter efficient fine tuning. Got it? And to drastically reduce the VRAM, we must fine tune the model in 4-bit precision, which is why we'll be using we'll be using LoRA here, not QLoRA. We'll be using LoRA here. Fine. That means we'll be loading our model in a 4-bit precision. I think I already explained here what is 4-bit precision, right? So initially your weight would be in the full precision. Okay, 32-bit precision. This is called full precision, and we'll be loading the model in the 4-bit precision with the help of LoRA technique. Fine. I think it is clear now. Now let's load the model, guys. Now you can load the official Llama 2 model. You can see you can also load the official Llama 2 model. So Llama 2 is having also official model. So this one. So see, this is the official Llama 2 model. You can load, you can copy, and you can just paste it here. But if you didn't get the permission, what you can do, you can also load the model from any other repository. So see, this repository has having this model also. This Llama 2 7B chat HF model. So this repository has already published. And here you don't need to take the permission. You can directly download the model. So if you haven't get the permission, you can use this model. Either you can use the official model. Okay, official model. Let me also copy here and let me mention it here. Let's say I can comment here just for your reference. You can copy the name and you can paste it here. Okay, later on. Now this is the dataset, guys, I'll be using. I think you remember. So this 1K example we'll be using. So copy the name and try to mention it here. Okay. And after fine tuning, what is the name you want to assign? I want to assign this name Llama 2 7B chat fine tune. And these are the LoRA parameter, you can see. And LoRA parameter wise, everything just keep it default, because you can see I'm loading everything in a 4-bit precision. Okay, 4-bit precision. So no need to change anything, keep it everything as default. See, I won't be changing anything. Only the change you have to do, the epoch size, number of epoch you want to train. So I think epoch I have mentioned here somewhere. See, number of epoch, training epoch. So as of now, I'm showing you one let's say epoch training, because one epoch training will take time if you're using free collab. And if you're doing the actual training, that time just try to increase the epoch size. Now everything keep it default, no need to change anything. Now let me initialize all the parameter. So this is my LoRA parameter, guys, for the parameter efficient fine tuning. Fine. Now we'll be loading the dataset. I want to use the training dataset because I want to do the fine tuning. And here I'm loading everything in a 4-bit precision, you can see. Okay, with the bits and bytes actually configuration, we are loading everything in a 4-bit precision. So this is the way actually we can define our LoRA. And how I got this code, if you go to the Hugging Face documentation, you will see that, okay, they have already given this kinds of code snippet. So you just copy paste and try to use it as it is. No need to change anything. Fine. Now see, here I'm loading the model in a 4-bit precision. So here you can see I'm loading the base model as well as the tokenizer. Okay, tokenizer I'm also loading. So guys, here you can see I'm setting all the LoRA configuration. After that, here is the training arguments. I think you know what is training arguments. In the Hugging Face, you have to set your directory, the number of epoch, your optimizer, everything you can set here. Then with the help of SFT trainer, I'm initializing the training process. You can see model.train. Now see, if I execute this code, it will start the training. But see, training will take time actually, around 30 minutes actually it will take. I was training previously. I know that it will take around 30 minutes. Okay, 30 minutes you have to wait because here we are using free Google Colab. So as you can see, it is downloading the model. After that, you will see that it will start the training. See, it's downloading the model. So see, I won't be waiting 30 minutes. What I'll show you, the next process actually you can follow. Like after training, what you can do. Because see, I have written all the code, only you just need to execute if you're doing it. Because here I'm recording currently So I can't wait actually 30 minutes to train the model. Let me show you what you can perform here. See, after training the model, you have to save the model. You can see you have to save the model, trainer, model, save, pretrain. Then you have to give the new model name. I think new model name, I think you remember, we have given a new model name here. Whenever we define all the configuration, this is the new model. Okay, so it will save with the help of this model. Fine. So it will save the model in the here in this disk. Actually, you'll see that it will create an output folder. Inside that, it will save the model. Then after that, you can also visualize the TensorBoard logs. See, this TensorBoard will show you the losses, then the accuracy, okay, of your model. Everything it will show you. That means the complete metrics it will show you. The training losses, validation losses, everything it will show here. Then after that, what I was doing, I was loading the original model. You can see I'm loading the original model, not the trained model I've trained. I'm loading the original of the Llama model, and then I'm testing with a prompt. What is large language model? I just wanted to see what would be the output from my original large language model, because that means I want to compare this result with my trained model, the model I've trained right now. Okay, that's why I'm loading the base model. That means my original model, and I'm only want to see the output. Okay, so here I've given a prompt, what is the large language model, and this is the actually output I got, okay, from my model. Then after that, what I did actually, I deleted all the model pipeline and everything just to empty my VRAM, because in RAM actually it will occupy lots of space. So you have to execute this code after executing this line actually. So no need to execute this line of code, just try to skip as of now. First of all, is execute this line of code. This line of code, what it will do, it will try to load your base model as well as your trained model. Okay, that means new model. Then it will merge. That means if you want to save the model right now, if you're using parameter efficient fine tuning, first of all, you have to load your base model as well as your new model. Okay, both you have to load. Then after that, you have to merge. After merging, what you can do, you can also load your tokenizer. Then you can push this model to the Hugging Face hub. For this, just execute this line of code, and you have to perform the Hugging Face CLI login. Okay, Hugging Face CLI login, and it will ask for one authentication token. See, this is the token it will ask. Now what you have to do, go to the Hugging Face, go to the settings. I think you know how to generate the tokens. Go to the access tokens. Now create a new tokens. Let's say I'll give the token name is equal to test. And now you have to give the right access, because you want to write something. You want to push something to the Hugging Face hub. That's why you have to give the right access. Now create the token. Let's create the token. Now copy the token and pass the token inside that. Inside that, you have to pass the token, then give Y, then press enter. After that, it will automatically authenticate with your Hugging Face. Then it will be pushing your model to the Hugging Face itself. Now here you have to give your username. See, this is my username, ENT Bappi. So make sure you are giving your username here. Okay, not my username. Otherwise, it won't be working. Okay, so if you execute this line of code, it will push your model as well as the tokenizer as well. Now, after executing this line of code, go to the Hugging Face, click on the profile, go to the, let's say, your profile. Now you'll see that in the model section, this model would be published. Okay, and this is the model, and this is your tokenizer. That means the same model you have to use for the tokenization as well. I think I already showed, right? Now, after that, let's test this model, okay, whether it is working or not. So for this, I created another notebook. Let me show you. So this is the notebook I created, guys, fine-tune model test. Now, again, just try to install Transformer Accelerate. That means all the required package. Then after that, just try to load your model right now. The model actually you have trained. See, this model, just try to copy the name and just try to paste it here. Okay. Then again, I'm giving the same prompt. What is the large language model? I'm loading the tokenizer first of all. So inside this pipeline, I'm giving my model. Then after that, you can see I'm creating the complete pipeline. Then it is predicting and it is giving me the results. Now see, this is the results actually I'm getting. See, although I've trained only one epoch, but if you see the results, it's not actually bad. Somehow actually it has given me the good output. Then again, I have given another actually prompt. Now see, this is the results. I'm executing my model and this is the results actually I'm getting. So the prompt is actually explained to me in a simple to understand way. What is the equation of finding the nth triangle number is and how it can be provided by using the high school level math. Please give each step of a proof of using LaTeX. See, this is the LaTeX actually output I'm getting. That means all the, let's say, mathematical equation and everything it has given me as a LaTeX. Now I can convert this LaTeX to the mathematical format and you can see that particular output. Okay, so that's how actually we can also test our model. And this is the entire process of fine tuning, guys. Entire process of fine tuning. And see, still training is going on. You can see still training is going on, and it has created the result folder. And inside result, inside branch, it will save the weights. Okay, it will save the weights. That means the artifacts. Fine. So yes, guys, that's how actually you can perform the fine tuning operation with the help of parameter efficient fine tuning. You can use either LoRA, either you can use QLoRA. Fine. So now what you have to do, guys, just try to perform this fine tuning. And if you are having any error, if you are having any issue, you can let me know in the comment. I'll try to help you with that, okay, to fix that particular error. Now apart from that, just go to the Hugging Face, try to pick any other model, guys. Go to the Hugging Face and pick any other model, not this Llama 2 model. You can also take Llama 3 model. You can also take, let's say, Mistral model, Falcon model, any kinds of model you can take. Just go to the model section, just find a model and try to perform the fine tuning process. Okay, you can use the same technique to perform the fine tuning process. Fine. So in future, I will create some more video there. Actually, I will show you how we can fine tune any other model as well. Let's see if we want to fine tune the Gemini model, how we can do it and all. Okay, we'll be creating some more video. But before that, first of all, try to explore by yourself. The way actually I showed you, the entire notebook I shared with you. Try to pick up any kinds of model and try to follow the same technique to perform the fine tuning operation.
So LlamaIndex is nothing but it's an alternative framework of LangChain. So LlamaIndex gives you the ability to build a very powerful generative AI application with the help of large language model. So whatever things actually we have learned with the LangChain, like we saw like how we can use LangChain framework to build generative AI application. The same things can be performed with the help of LlamaIndex as well. So this LlamaIndex and LangChain is like very popular in the market nowadays. So people are using LlamaIndex and LangChain very broadly in their generative AI application. Now it's up to you like which framework actually you will be choosing whenever you are developing any kinds of generative AI application, right? So we have learned like LangChain, like how we can develop generative AI application with the help of LangChain. Now it's time to also explore like this LlamaIndex one. So in this video, actually, I will give you like how we can build generative AI application with the help of LlamaIndex. So this is going to be one amazing video altogether. Just try to watch this video till the end and don't skip any part of this video, otherwise you might get some issue. And if you have some query, you can let me know in the comment. I will happy to help you. So guys, let's start with our video. So first of all, I will take you through the LlamaIndex documentation, then I will start with our project implementation. So guys, this is the LlamaIndex documentation, and LlamaIndex is nothing but it's a simple flexible data framework for connecting custom data sources to the large language model. So basically LlamaIndex is nothing but it helps you to build this kinds of generative AI application with your custom data, as well as it will also give you the ability to connect with these kinds of large language model we have seen, right? So it is the similar kinds of framework of your LangChain. So whatever functionality LangChain provides, your LlamaIndex will also provide that one, but some of the syntax would be a little bit different. Okay, so I will discuss this thing whenever I will take you through the project demo. Okay, whenever I will be building projects with the help of LlamaIndex, at that time I will show you like why what is the syntax change actually you need to consider. Now guys, you can go through the documentation. They have written everything. Okay, so here it is telling we can easily build like lots of generative AI application with the help of this LlamaIndex. Even you can connect with these kinds of unstructured data, structured data, and semi-structured data. So unstructured data means text data, PDF data, video data, and it can be also image data. Structured data means you can also connect with Excel data, SQL data, and so on. And semi-structured data means like you can also connect with the API. Then you can also with this Slack, then Salesforce, Notion. So these kinds of platform you can also integrate to collect the data with the help of this LlamaIndex. Okay, so this is one of the very popular framework in the market, and it is like very powerful. So you can use this one also to build your generative AI application. So it's fine you if you know like both framework like LangChain and LlamaIndex. So it will help you to build like very powerful generative AI application, right? So I personally like this LlamaIndex a lot. Okay, I usually use LangChain to build my generative AI application, but I also like this LlamaIndex. Sometimes I also use LlamaIndex to create my generative AI application. And guys, this is the documentation of this LlamaIndex. So there actually they have given how to set up this LlamaIndex and what are the things actually it provides. See, it has also this agents, then chatbot, structured data extraction, then indexing, everything like whatever you have seen inside your LangChain, everything it has. If you see here, all the things actually they are providing. So you can go with the documentation. So they have given each and everything. Now I'll quickly show you like how we can set up this LlamaIndex on our Google Colab, and how we can build like one basic generative AI projects with the help of this LlamaIndex. Okay, then it would be very much clear for you. So first of all, what I will do, I will open my Google Colab. So let me open my Google Colab. So here I will create a new notebook. Here you can give the name. So I'll just give LlamaIndex demo. And here make sure you have selected runtime as GPU. So let me select runtime as GPU. And let me connect the notebook. So in between, what I can give you, I will give you the project architecture, like actually what I'm going to do exactly with the help of this LlamaIndex. So for this, actually, I'll open my Blackboard, and here I already kept this project architecture, as you can see. So basically here we'll be building one projects. Basically here we'll have lots of like documents. So basically we'll be chatting with the documents. Okay, so chat with multiple multiple documents. Okay, so this is the project name. So it can be any kinds of documents. So it can be PDF, it can be, let's say, doc, it can be txt. Okay, it can be image, anything you can give. So we'll be extracting the data all together. Okay, then we'll be chatting with these kinds of documents. So this is nothing but our custom source. Okay, so this is nothing but our custom data. Okay, or custom data source you can talk about. Okay, and here first of all what I need to do, so user will give me these kinds of like data, custom data. So I need to extract the data, and after extracting I also need to convert them to chunks, because I already told you what is this chunks and why we need it. Because here I'm going to use large language model. Okay, LLM, I'm going to use large language model. So LLM wise I'll be using something called Google PAM, Google PAM 2. I already discussed like Google PAM 2. And if you already know, Google PAM 2 has one specific input size, which is nothing but 8090 tokens. Okay, so if you're extracting the data altogether, so it might be more than 8096 token. So that is why it's better to create a chunks. So instead of giving all the corpus together, I will provide as a chunks to chunks, so that my input size it can handle very easily, right? So that is why chunks is important. So after creating the chunks from my entire corpus, I also need to convert this text to vector. Okay, I'll be converting text to vector. So for this, actually, I'll be using some embedding model. So in this case, actually, I'm going to use Hugging Face embedding model, Hugging Face, Hugging Face embedding model. You can also use PAM2 embedding model. It's completely fine. I already showed you how to use PAM2 embedding model. You can also use Hugging Face embedding model. Then after creating this vector store, I also need to store, these are the vector, okay, in a knowledge base. So by default, actually, this LlamaIndex has one functionality. So it will create a knowledge base in your local. I will show you like how to create it. Then after that, we'll be handling the user. So user will raise some query. So we'll first of all convert that query to query embedding. Then we'll be performing something called semantic search. So it will give me some rank results, and we'll be applying generative model, that means large language model, to get our actual response. Okay, so this is the complete idea of our project architecture, right? So now let's implement with the help of this LlamaIndex. As of now, we have seen like how to implement with the LangChain. We have seen like how we can develop end-to-end generative AI projects with the help of LangChain and vector database and so on, right? So same thing you can do with the help of LlamaIndex. You can also add your vector DB here. You can use Pinecone. You can use Weaviate, you can also use ChromaDB, anything you can use. But here I'm not going to use any kinds of vector DB. I'm going to use default knowledge base providing your LlamaIndex. Okay, so it will store your vector in a local. I'll show you like how to do it. Okay, you can also connect with the vector DB, so that can be also done. I already taken lots of session on it, so you can go ahead and watch it. So guys, now let's see like how we can set up this one. So to set up LlamaIndex, there is a Python package actually you will get called LlamaIndex. Okay, so just write pip install hyphen q LlamaIndex. Okay, llama hyphen index. So this is the package name you need to install. If you visit their documentation, and if you visit their installation guideline, okay, if you visit their installation guideline, see, this is the LlamaIndex package they are using. Okay, now I also need to install something called PyPDF, because here I'm going to use PDF data. So let me install PyPDF, Py PyPDF. Then I'm also going to install something called doc to text, because I'm going to use also doc type data. So I'll just write pip install doc docs to text txt. Okay, this package I need. Then I already told you I will be using Google PAM2 as my large language model. So for this, actually, I need to install something called Google Generative AI. So pip install uh, Google Generative AI package. Okay. Now I will be using something called high face embedding. So for this, I need transformer. So I'll install transformer. So pip install transformers. Okay. Now let me install them together. So guys, installation is done. Now I'll import some of the libraries. So let me import. So first of all, I will import something called simple directory reader and my vector store from my LlamaIndex. I'll tell you like whenever I'll be using it. So these two function I need. So these two function actually I need called simple directory reader and my vector store index. I'll tell you like whenever I'll be using. So what is the use of it? Then I also need something called PUM model. So it is already available inside LlamaIndex. So as you can see, LlamaIndex .llms PUM, and I'm importing this PUM. And this is the similar things actually with the Langchain as well. So I think you remember we are also importing PUM2 model from Langchain. So from Langchain.llms, then I was also importing this PAM model, right? So if you have already used LangChain, so using this LlamaIndex would be very much easy for you because lots of functionality will remain same, will look like similar to you. So some of the functionality and syntax might different, but rest of the things are I think similar. Okay, what I feel like. Then I also need something called service context from LlamaIndex. I'll tell you like what is service context. Then I also need something called storage context and this load index from storage. Okay, these are the thing. Then I also need something called operating system package. Now let me import them. Okay, done. Now I will load my data. So here let me comment out load data. So to load the data, first of all, here what I will do, I will create one directory. So here I'll just write one command mkdir and I will name this directory as data. Now if I refresh, I think directory has created. Now here I will upload some of the data, that means documents. So I can upload, see here I have PDF as well and this docs data as well. So let's upload these docs first of all. So this is the like LlamaIndex documentation, as you can see. So it is present inside my docs file. Now here I will also upload this one YOLO. Okay, YOLO PDF. So with the help of this simple directory reader, we can load everything, any kinds of file format you can load. Okay, so that is the power of this LlamaIndex. But if you used, I think Langchain, you remember, we used to use something called PDF loader, then TXT loader, separate file. But if you're using LlamaIndex, so you can directly load them together. Okay. So these kinds of some functionality will might vary and will look new to you. So it's completely fine, but functionality are same. So guys, let me show you like my data once, like what are the things I have. So in this LlamaIndex docs, I have some content related LlamaIndex, like what is LlamaIndex and all. Okay, so here is the content I prepared and it is present inside these documents. Then in the PDF, actually, we can see this is a YOLO related PDF. So what is YOLO and YOLO architecture? So these are the content are available. So you can ask any kinds of query, any kinds of question from these documents. Okay, you have submitted. So we'll be doing that with the help of this large language model and with the help of this LlamaIndex. Okay. So guys, as you can see, my data has been uploaded. Now what I can do, I'll first of all load the data. So I'll extract the content from these documents and PDF. So for this, I'll be using something called this simple directory reader. So I'll call it, and inside that you just need to provide the directory. So this is the data directory. Inside that I have this data, and here is one function called load underscore data you need to call, and I will store it inside a variable called documents. Okay, now let me load them. Yeah, now if you want to see the data, so this is the data it has extracted. Okay, and this is in a document format, as you can see. Okay, and it will also give you the reference ID and if you're using any embedding or not. So it's none by default because we haven't used any embedding, and this is the content it has extracted. Okay, now what I need to do, guys, we have successfully extracted the data. Now I need to perform something called chunking operation on top of it, because this is my entire corpus, and I also need to convert them to chunks. So for this, let me just first of all comment. So we'll be performing split text into small chunks. So before that, first of all, I need to set my Google API key. Okay, Google API key I need to set. So the using this Google API key, we'll be able to access our PaLM model. Okay, from this uh, Google PaLM API. So if you open this Google PaLM website, so here they are telling just try to create one API. I already showed you how to create the API. Just click on this PaLM API, and here you just need to get your API key, and here you can generate a new key. Okay, so for me, I already created one key. So this is my key I already created. So if you don't have any key, you can create from here. So guys, I already created the key. So this is my key, and don't share this key with anyone. I will remove it after the recording. So that's why I'm showing. Now let me set this key as my environment variable. Done. Then I need to initialize my LLM. So LLM wise, I am using something called this PaLM model. So it will automatically authenticate using this API key. Okay, so PaLM is not initialized. Please install Google Generative AI. I think we have already installed this package. Why it is giving? Okay, let me install it. Okay, I need to restart the runtime, so that is why I think it was not working. So guys, we have restarted the runtime. Now let me import them again. Now I think my documents is already there. Okay, so I need to again load the documents. Now this is my data. Now I'll set this API key. Now I load my PaLM model. Okay, it's loaded. Now see guys, initially whenever I was using LangChain, so we used to create these chunks in a different way. We used to use something called text character splitter function to create these chunks. But here this things is a little bit different. So here you need to use something called this service context. Okay, so here is a service context function. You need to use this function. So here you just need to initialize it. So it has one method called from documents. So from no sorry from default. So from defaults, and here you just need to pass the LLM at the very first. So LLM wise, so PaLM is my LLM. Then I also need to give the chunk underscore size. I think you already know what is chunk size, so it will like split your data with respect to that. And I also need to define something called chunk overlap. Okay, so overlap, so let's give 20. So chunks overlap helps us to understand the context of my entire corpus, because it will convert to chunks, and to get your previous context I need the chunks overlap. I already explained this thing in my vector database session. Now here you can also give like embedding, which embedding you want to use, and if you're not giving anything, so by default it will use that Hugging Face embedding. I'll show you. So service context, this is my service context I got. Now if I execute this code, you will see it will first of all Okay, it's giving one error. No API key found for OpenAI. Okay, it's giving the error because I need to again install this transformer, I think. So let me install the transformers. So guys, as you can see, it's giving one error. It's telling no API key found for OpenAI. So here, by default, if you are not giving any embedding model, so it will try to take the OpenAI embedding model. But here in this case, we haven't provided any OpenAI API key. So that's why it's throwing error. So if you visit this URL, so they're telling if you want to use some other embedding, so you need to first of all import it. So let me import this Hugging Face embedding. So I told you I'll be using Hugging Face embedding. So first of all, let me import this Hugging Face embedding here. You can also use Google PAM embedding the way I showed you in my previous project. You can do it, but let's use this Hugging Face embedding. Now I need to create one object called embed model. So here I can create. Now here I'll be using this model. This is the model available in the Hugging Face. This is the embedding model. So I need to install something called sentence transformer for this. So this is the command. Let me install it here. Done. Now let me import it. Now guys, see, first of all, it will download that embedding model from Hugging Face. Then it will load that. So done. Now I need to give one parameter here called embed model is equal to embed model. Now let me execute it. So my service context is prepared right now. Now what I will do, now what I need to do, I need to convert my documents to chunks, and that chunks I need to convert to something called vector embedding. Okay, so for this, you need to use something called uh, vector store. Okay, so vector store, I think we have already imported this thing above. So this is the vector store index. So this class will help me to do that. So let me import it here, and it has one function called from documents. Okay, so here you just need to give your document. So in this case, I have my documents here, I think you remember. So this is my documents, this is my entire corpus. Then I also need to give my service context. So service context equal to my service context. This is the service context, so it will take the model and everything from here, and all the configure I have set here, chunk size, chunks overlap, everything I have given here. Now I will get my something called index here. So in LlamaIndex, the vector you get, we call them index. Okay, so this is my index. Now let me convert them. So it is taking some time because it is taking all the documents and converting to chunks and converting to vectors. Okay, now we have successfully converted them. Now I need to store them in my local. So let me comment it here. So to store it, first of all, call this object called index, and there is a method called storage 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 context dot persist. Okay, now if I execute this one, you will see it will save everything as your local. Okay, so there is a folder it will create called storage. Inside that, see all the vector it has saved. Okay, now you can open it, anything, you can see that. Okay, see, this is the data it has saved. So it follows one particular format to save your documents. So it might not understandable to you, but this is my, see, this is my vector. Okay, this is my final vector of my entire data. Now guys, we have successfully stored our indexes. Now let's see if you have some existing storage, all existing index already. So instead of creating them, you can directly load it. So this is the code. So this is the code, load the index. So here you need to call storage context. I think you remember we imported this thing, storage context. So using storage context, there is a method called from default, and here you just need to give the persist directory, which is nothing but storage, and it will load that. And to load it, you need to use load index from storage. Okay, we imported, I think above, you remember, load index from storage. Then it will load that index for you. Okay, it will load that index for you. So you can execute this code. Okay, I already created my index object, that's why I will comment it out. Okay, I'll comment it out. You can if you have already, so you can load it out. And here you can also use like vectordb to store these other data to your vectordb as well. Okay, this is also possible, but LlamaIndex provide this functionality, so that's why I am showing this functionality to you. Okay, how to store them in a local machine. Now we can perform our QA operation, QN operation. So let's do QA operation. So here, first of all, you need to define one query engine. So this is my index. So it has one parameter as query, as underscore query engine, and this is my query engine. Now I'll call my query engine, and here I will ask the query. So this is my query. So here, first of all, I will ask like, what is LlamaIndex, because I have one LlamaIndex related documentation here, right? So that is why I'll ask, what is LlamaIndex? And it will give you the response, and this response I will print it here. So guys, this is my response. Again, it's not understandable. So if you want to extract the actual response, if you want to see the actual text, so for this you can use this package, because we are using Google Colab. So there is a package called IPython display, markdown and display. So these two packages I will be importing. Then I'll be using something called display.markdown, and here I will give my response. Okay, the response I'm getting now, if I execute it, so it should give me the response. See, LlamaIndex is a data framework for building an LLM application. It provides a comprehensive toolkit for integration management and query of your external data, so that you can use with your LLM app. Great. Now you can ask any other query. So let's say I have one YOLO documentation, so I can ask anything about YOLO. So what is YOLO? Now if I execute again, see, YOLO is a regression algorithm. It takes image input and output, building bounding boxes and level images. Okay, great. Now let's say if I'm asking anything out of this context, out of this data, so let's see what happens. So I'll ask who is Bappy. Let's say I will ask this question. See, it's telling Bappy is a random name, and it's not mentioned in the context. So basically, we have created these projects, and basically it is only relying upon our custom data we have given. Okay, apart from that, if you're asking anything, so it won't be giving the answer. So you can ask anything like related to your documents. So in this case, you can use this question, anything you can ask, like whatever question actually you have, so it will give you the answer with respect to that. Yeah. And this project actually you can convert to Streamlit app. I already showed you how to convert them to Streamlit app and all, so you can try this thing from your site. Okay, I think you can do it. So yes guys, this was all about LlamaIndex. I hope you get it, like how we can use this LlamaIndex as our alternative framework of our Langchain. And this is one of like good framework, I can say. So you can visit the documentation and you can learn so many things about LlamaIndex. Okay, now try to explore from your side, so you'll be getting each and everything.
I think you already know about LlamaIndex. I already explained what is the LlamaIndex. LlamaIndex is nothing but it's a alternative framework of Langchain. That means whatever, let's say, things you can perform with the Langchain, the same thing you can also perform with the LlamaIndex. So both are actually generative AI framework. With the help of that, you can create generative AI based application. So in our previous video, we saw like the entire introduction of the LlamaIndex. So there actually we already performed one practical example. So in this video, I'll show you how we can use open source large language model with the help of LlamaIndex. So as an open source model wise, I'll be using something called Mistral. Okay, so if you don't know, Mistral is an open source actually large language model, and it is available inside Hugging Face. Now, if you search here, let's say Mistral, if I search here, see Mistral is having actually different model. Let me show you. So let me go to the Mistral AI. See, it is having actually 17 different model. So expand all the 17 different models. See, Mistral is having 7B model. That means this is the 7 billion model, 22 billion model. Okay, that's actually it is having different model. So from this model, guys, I'm going to use one model called Mistral 7B Instruct V01. So this model actually will be using with the LlamaIndex. So this model will be downloading from the Hugging Face hub and will be using with the help of LlamaIndex. Okay, so here I'm going to create a simple system. So let me show you the diagram, what I'm going to perform here. See here, I will upload one actually PDF document. Then I will extract the data, extract the documents, extract docs. After that, I'll perform chunking operation. I think you know what is chunking, okay, and why it is required. Then I'll be using one embedding model. Here I'll be using one open source embedding model. Fine. Embedding model to generate the vector embedding. So it will give me something called vector embedding. And this vector embedding I'll be saving to a knowledge base. That means vector database. And if you're using LlamaIndex, guys, I think you already know LlamaIndex has one vector database service. So we can call it as vector store. Okay, vector store. So inside vector store, we can save our embeddings. Okay, whatever embeddings actually will be generating, and we'll be using LlamaIndex. Okay, LlamaIndex vector store. Okay, LlamaIndex vector store, and this is going to be my knowledge base. Then after that, user will ask one query. Let's say this is the user. User will send one query to the knowledge base, and knowledge base will return some relevant answer. Okay, it will give you some rank results. Then what I have to do, I have to use one large language model, LLM. So here I will be using something called Mistral. Okay, Mistral. So we'll pass this rank results to this large language model as well as this query as well. So this query and this rank results will process your large language model, and it will give you the actual response. Okay, it will give you the response. So this is the system actually will be implementing. Fine, with the help of LlamaIndex as well as the open source large language model, because this system we already saw how we can implement with the help of Langchain. Now let's try to see how we can use the LlamaIndex as well. So let's get back. So here I already created one notebook, guys. You can see Mistral with LlamaIndex. So first of all, let's connect this notebook. So resources would be shared in the description section. So from there you can download and you can execute all the code. So it is connected. Now let me check the GPU, which GPU actually I got here. So I'm using Colab Pro, guys. So that's why I'm using A100 GPU. So if I go to the runtime, change runtime type C, I'm having A100 GPU. So if you're using Colab Pro, so you can access this GPU. Otherwise, you can select T4 GPU. Okay, it's completely fine. Now let's install the PyPDF, because I already told you I'm going to use PDF data here. And I have to upload one PDF documents here. Okay, but before that, let me complete the installation. Then I'm going to install the transformer. Then I am also going to install some required package for the transformer. Okay, so let me install everything. Why transformer? Because I want to access this Mistral model, and this model is available in the Hugging Face app. And then I need to install something called sentence transformer. Why? Because I already told you we'll be using open source embedding model, and for this I need this sentence transformer. So let me install this as well. Now I'm going to install the LlamaIndex. So I'm installing one specific version. Why specific version? Because I already told you if you're installing any specific version, that will help you a lot in future. Because let's say today you have created one project with the latest LlamaIndex. What will happen after some days? Actually, they will upgrade their package, and again you will get issue, right? So that's why it's always better practice to use one specific version. Fine. Now let me import all the required libraries. So you can see I'm importing from LlamaIndex vector store index, simple directory reader, service context. Okay. Then Hugging Face LLM, then simple input from. So this is the vector store, guys. That means this is the vector database service LlamaIndex provides. So here actually we can create a knowledge base and we can store our embedding. And this is the local DB. Okay, it will save everything in local. Then simple directory reader will help you to read your content. That means whatever data actually will be reading, right? Then Hugging Face LLM will help you to load that Mistral model. Then with the help of simple prompt, you can create a prompt template. Fine. So now let me import all of them. Later on, I'll tell you whenever I'll be using them. Now here I'm going to create a directory called data. Okay, because inside data directory, I'm going to upload my data. Now see if I refresh here, data is created. Now let me upload one PDF here. So guys, I'm having one statistics PDF. So I'm going to upload it here. So let me show you the PDF. So this is the PDF document, guys. Importance and use of correlation in statistics. So this PDF actually I'm going to upload in my Google Colab, and on top of that actually will be performing this operation. Now here you can use any kinds of PDF, any kinds of documents. Okay, whatever you have. Now see, it is uploaded. Now let me read the content. So inside simple directory reader, you have to give the data location. So you can see I've given the data folder. It will automatically load the PDF and it will extract the information. Let me show you. See, if I show you the documents right now, see all the document is has extracted. Fine. Now here, first of all, let's create a prompt. So here you can see I have created a system prompt. You are an QA assistant. Your goal is to answer the question accurately as possible based on the instruction and the context provided. Now this system prompt actually I want to use as a default prompt inside my large language model. For this, you have to create one query wrapper prompt. For this, you can use simple input prompt. Okay, and inside that you can pass these are the keyword. Fine. Now let me execute. Now you have to do the Hugging Face CLI login because this model is available inside Hugging Face. And to authenticate with Hugging Face, you have to give the token. Now here you have to pass the token, and how to get the token, guys? I think you remember. Go to the Hugging Face. Click on the profile. Go to the settings. And left hand side you will see access token. You can create a new token here. So let me give the token name, let's say test. I want to give the read permission as of now. Let's create the token. I'll copy and let's mention it here. If I paste it and hit enter, it will automatically authenticate. Now here it is asking token as greet credential. I'll give yes. Now see, login successful. Okay. Now you can see this is the model link I have already given. So this model actually will be using. Now let's load the model. And to load the model, I'm going to use Hugging Face LLM. Inside that, you can pass context with the max token. I think you already know what is max token. So what is context window? Context window means this is the input size of this LLM. That means it can take 4096 token actually as input. Okay, as the input. That means this is the input size of your large language model. Mistral can take 4096 token. Okay. Now you can give this temperature parameter and all. And inside that, just pass your system prompt, whatever prompt actually you have defined here. I think remember. And you have to also pass the query wrapper prompt. That means the default prompt you want to set. And here you have to give the model name, like which tokenizer you want to use. I want to use the same tokenizer as per my model. See, this is the model. Okay, I'm giving the model ID here. Now you need to also give the model name. That means the same name. Then after that, auto map is equal to true. That means I want to use my GPU here. I want to load this model in my GPU because it's a large language model. It is having actually lots of parameter, right? So we can't let's say run this model on our CPU machine. It's not possible. If you're running, actually it will take lots of time. Even your memory will also get crash. So that's why we have to load everything in the GPU based machine. Now let's load this model. See, first of all, it will download the model from the internet and it will create one LLM wrapper. See, it's around 9.994 GB. Just try to consider, guys, how much big this model is. So that's why actually whenever you are using any kinds of open source large language model to create any kinds of LLM powered application, so this is the issue actually you'll be getting. That means you should have good configuration machine, otherwise you won't be able to use that model. So we'll be learning something called LLM ops. So inside LLM ops, actually I will show you how we can create an efficient LLM powered application, how we can deploy it also on the cloud platform. We'll be discussing each and everything. Because of that only LLM ops came in the market. There are so many platform actually we can use, like cloud generative AI we can use. Let's say Bedrock is there, Vertex AI is there, Azure OpenAI is there. We can use these are the service, okay, to overcome this issue. So this model has downloaded successfully. Now what I have to do, I have to download the embedding model as well. So to download this embedding model, I'm importing Hugging Face embedding from Langchain. So because Langchain is having one embedding functionality, so from there we can easily download the embedding model. So let's try to download this embedding model. So we have to install Langchain community for this. So let me install Langchain community. Now let me execute this code. So see, it has downloaded successfully. Now let's create the service context. That means my vector store. That means I will be creating the knowledge base. For this, we'll be using service context. From default, inside that you have to provide the chunk size. That means first of all, it will perform the chunking, then it will create the, let's say, vector embedding, and it will store that vector embedding to the knowledge base. Okay. Now inside that you have to pass the LLM as well as the embedding model. Now let's create the service context. So here actually some of the syntax are different. Okay, with respect to this Langchain. If you use the Langchain, I think Langchain syntax is a little bit different. LlamaIndex syntax should be a little bit different. But I mean, framework wise, both are same. Okay, both can perform the same thing. Now let me create the knowledge base. So here here I'm using vector store index from documents. Here I'm giving the documents as well as the service context, whatever service context we have provided. Okay, now it will create the entire knowledge base. Now I can perform the query operation. Okay, that means this operation. Okay, this operation. So it will go to the vector store, that means knowledge base, and it will return the rank results, and your LLM will process and it will give you the correct response. Okay, so here I'm given one question: what is the correlation? Now let's see what is the response I get here. So inside LlamaIndex, you need to write less line of code. But whenever you saw the Langchain, actually we have to write actually our vector store actually manually. That means we have to write some more additional code, right? But here everything is automated, everything it will handle. That means we don't need to perform the chunking separately. Chunking will automatically perform here. Okay, with the help of the service context. See, although I'm using GPU based machine, but still the inference timing is high here. Now see, it's done. Now if I show you the response, now see, this is the response I got. Correlation is a statistical measures that express the extent to which the two variables are linearly related. That means it has given me the correct response. Okay, so yes, that's how actually we can use any kinds of open source large language model with the help of LlamaIndex. Now you can go to the Hugging Face and you can use any of the, let's say, large language model, and you can use it with the help of LlamaIndex. Fine.
So I'm not going to implement these projects from scratch because I have already discussed the like process how we develop like one end-to-end projects. Okay, so that is why I already implemented one particular projects, as you can see here. So this is like a financial stock analysis project I have developed with the help of this LlamaIndex. So first of all, I will show you the demo of these projects. Okay, like what is the projects and all about. So those who are interested in the field of financial, or let's say in the domain of financial, so they will be loving this project because here you can do like stock analysis. Okay, so we have some stock data, we have some articles actually, as you can see. So these are the articles I have downloaded from the internet, and this is in the HTML format. So we'll be processing, these are the data, we'll be collecting the content. Okay, if you see, this is the completely HTML data. So here we have lots of like financial stock data, like we have Google data, then we have Nvidia, we have Meta. Okay, then we have MS here if you see MSFT. Okay, as you can see, so we have different like you can say companies stock data here. So I already given the link of the data in my GitHub, so you can download from here. I will show you like how to download the data. So that is script I have already written. So first of all, let me execute the project. So I will first of all execute this projects and show you like how it will work. So see guys, this is the Streamlit app I have developed, and here you can do two kinds of analysis. One is like you can do a single stock analysis, another is a competitive analysis. Okay, like competitor analysis. I'll show you both of you. Okay, so here first of all, let's do the single stock analysis. So I'll just ask what is the stock of, here if you see, so they have given the short name for each and every company. If you come here, so I've already listed down. So let's ask for the Nvidia. So I'll copy the Nvidia, and here I will ask. So guys, as you can see, I have asked like what is the stock of Nvidia, so it is giving me the answer. Okay, you can see it is giving like 2023 to 2027. Okay, it's giving the stock, as you can see. Now, and you can ask for any kinds of stock. Let's ask for the Google. So I'll copy Google, and here if I paste and enter, so now it will give me the stock of the Google. So that's how actually you can ask different stock related question. Okay, if you're interested in these kinds of stock and all, so you can ask lots of question and you can get the response with respect to that. Okay, as you can see, this is the Google stock answer it is giving. Now you can also perform like competitive stock analysis. So just select the competitive one. Now it will give you the interface of the competitive analysis. So guys, as you can see, this is the competitive analysis one. So now here you need to provide stock one symbol and stock two symbol. So let's do like MSFT, and I will also do for my NVIDIA. Let's see the competitive analysis between them. So see guys, this is the competitive analysis between them. As you can see, you can read it out. Okay. So not only that, you can see like competitive analysis between all the company. Here is the listed. Okay. And this is the symbol of the stock. Like you can't directly pass the company name. So you need to give the symbol. Okay. Because this is your custom data you have given like that. So yes guys, this is the projects actually I have developed with the help of this LlamaIndex. And this is very much interesting projects like in the field of financial domain. And you can see implement lots of thing with the help of this LlamaIndex. I think I already showed you like lots of like functionality and all, and I already showed you lots of things. Okay, with the help of open source model and all, you can implement anything. Okay, whatever you can think in your mind, you can implement anything. Just you need to try from your side. Okay, now guys, let me show you like how I have developed these projects. Okay, so this is the projects guys I have already developed, and let me show you. This is the code for the projects. Okay, so I'll explain each and everything, like whatever things actually I'm doing, and I've already given the idea about LlamaIndex and this Streamlit and all. So I think you are already familiar with these are the thing. Okay, I'm expecting. So that's why I'll be explaining the projects. Okay, instead of writing all the line from scratch. So first of all, let me stop the execution. Then I will remove this article folder because this is my generated folder. Then I will also remove this stories. Okay, stories, I think you remember stories is nothing but it's a vector store we created with the help of LlamaIndex, right? So both I have deleted. Now here is the readme file I have already shared, like what are the steps you need to perform. So here first of all you need to clone the repository. So this repository will find from the description section. So from there actually you can download the projects. Then you need to create one environment. Okay, Python environment using Python 3.8. Then you need to activate the environment. Then you need to install the requirements. So requirement wise, I mean using these are the requirements as you can see. So you are using LlamaIndex, then Streamlit, Python.env. Okay, and apart from that, I'm also using OpenAI and some you can say dependency package I'm also installing here. So this thing you need to install. I already showed you how to install them and all, how to create the environment in my previous project implementation. Then after that, you need to execute this app.py. Okay, but before running the app.py, you should have your data and you should have your vector store presence. Okay, otherwise it won't be working. So for this actually in the src folder, I have written some of the script. As you can see, first of all we need to fetch the data. So this is the link guys. So in this link actually this articles is available. I have already given this link, and this is hosted on my GitHub. So from here you can download those data set. Okay, download those articles, and after that see I have written one function. With the help of this function I am downloading. So basically it will take this URL, data URL, and it will download that zip file, okay, from my GitHub, and it will unzip it. Okay, it will unzip it here, and that zip file it will remove. Okay, so this is the code I have written. Now let me show you how it is working. So I already created the environment. So now I'll execute this particular file. So I'll just write Python inside src. Inside src I have one file called 01 fetch data. Okay, I will execute this file. Now see guys, it will download that data from my URL. So see guys, it has downloaded all the HTML file, and now see if I open my articles, all the data are present. Now what I need to do, I need to create one vector state. I think you already know like what is vector state. I already explained these are the thing in my notebook experiment. Okay, what are the steps I perform, same thing I'm doing here also. Okay, so to create the vector store, I created another file called indexnews.py. So here I'm using this GPT vector store to create my vector embedding. So here you can also use Google PAM embedding. You can also use Hugging Face embedding. Anything you can use. Just try to use open source embedding because if you don't want to use like OpenAI, so if you don't want to spend money, so you can go with like open source model. Otherwise, if you have like OpenAI account, you can also use OpenAI API key. So here if you see, I have already set my OpenAI API key. So by default, if you're not giving any embedding models, it will take that OpenAI embedding model. Okay. So this GPT vector store index already has like GPT based embedding model. It will take that model and it will convert your data to vector embedding. Okay, so guys, this should be your task. Just try to replace this code with your open source model. I think I showed you how we can use Hugging Face embedding model in this notebook. See guys, here Hugging Face embedding model I was using. See, you also need to use Hugging Face embedding model here. Okay, in this case I'm using OpenAI, so you need to replace with the Hugging Face embedding model. Okay, I think I already showed each and everything, so you can do it. Now let me first of all generate these are the embeddings. So I'll clear, then I will run this second file. So it's 02. So it will take time because it will take all the articles, it will convert to chunks, then it will like convert them to vector embedding. Okay, then it will create the stories here. So here you can also integrate like vector database, so you can use Pinecone, Weaviate, and you can also use ChromaDB. But I'm using this default like vector store index. So LlamaIndex provide this thing, so it will store your embedding local. Okay, it will create one storage folder and it will store here. So you can also use a vector database, and you can store them in the cloud as well. Okay, I already showed you. Just try to integrate here. So guys, as you can see, my storage has been created. Now this is my vector. So see, these are my embedding. So these are my vector. Okay, so now we are successfully able to store our vector embedding. Now see, now this is the third script I have written. So if you want to test on top of your like storage, so here I'm loading the storage, and I'm just asking one query like, what is tell me about Google's new supercomputer. Okay, so this is the query I'm asking, so it will give you the response. So you can try out. Okay, so let me execute and show you how it is working. So I'll just write Python. Then inside src, I have this 03. Yeah. So see guys, this is the response I got. Okay, so yeah, that means my storage has been created successfully, and we are also able to ask the query on top of it. Now we'll be converting, these are the thing, okay, as our app. So basically I will give some of the input. Okay, user will ask the query, and they will also select like they want to perform like say single stock analysis, or let's say multiple stock analysis. So this kind of functionality I'll also add. So for this I have already created one app.py. As you can see, this is the app.py. Here if you see, my index is already created, so that's why I'm importing the storage context and load index from the storage, because I want to load it. Then I'm also importing like LLM wise OpenAI, because I told you I'll be using OpenAI like model here instead of using open source. So here you just need to replace this OpenAI model with your open source model. You can also use Palm2, then you can also use Llama 2, anything you can use. I already showed you this thing in my this notebook experiment. Okay, in my LlamaIndex session, just try to replace that. These are the model here. Then model wise, see, I've initialized GPT 3.5 turbo. Then here I'm just defining my LLM predictor. And I think you remember we had created one service context. Okay, so in LlamaIndex we create something called service context, and this will take your LLM. So what is done, I'm also loading my storage, that means this vector embedding. Okay, as you can see, I'm loading, I'm giving the path. Once it is done, I'm creating this query engine. Okay, so once query engine is ready, now we'll be creating the front end part. So here basically if you see here, we are creating this title and all, like this is the title, financial stock analysis. So let me execute and show you how this thing will look like. So see guys, this is the title and this is the report subtitle. So these two I've created. Now here I'm creating one select box. So what type of like report you want to you want. So this is the select box, guys. Let me show you. This is the select box. So if you want to create any kinds of select box, you need to select select box from Streamlit. And here is the message I've given. So what type of report you want to do, and a single and competitive. So here if you see these two things I'm giving here. So single and competitive. Then if user is selecting single one, okay, so first of all we'll be handling the single. So here is the prompt I have written. Let me show you. So I'm just using my engine query engine. So as you can see, query engine we have already created, and this is the like prompt I'm just giving. So write a report on like on the outlook for symbols. Okay, symbol, user will give me that. Okay, user will give me that symbol, because as you can see we are receiving the symbol. So as a text, input text, basically here is the symbol as input text we are receiving, and that thing we are passing here, okay, as a f string. Then once it is done, this is my prompt. Stock from, I'm just mentioning the year. I need this stock from this year. And I'm also telling like be sure include the potential risk and the headwinds. Okay, so this is my prompt I have given to my LLM. So my LLM will give me some response, and that response actually I need to showcase. Okay, so I'm just using st.write, and I'm just passing my like this response, and it will show here. So once it is done, so I'm also handling the competitive analysis. So if user is selecting competitive analysis, so first of all I'm taking like 2 competitive. As you can see, if I select the competitive one, so here if you see I'm receiving the stock 1 and stock 2, and this thing actually I'm storing symbol 1, symbol 2, and this is my second prompt. Okay, so I'm just write a report on the competitive between my symbol 1 and symbol 2 stock. Okay, then it will give me the response, and that's the response I'm showing in my front end. So this is the simple logic actually I have written behind these projects. Okay, and this is like very easy. Now you just need to like convert them to open source model, and if you have any idea on top of it, you can also create it. Okay, I think you got the overall idea, and all the resources actually will get from the description section.
So I think you already know what is medical chatbot. Let's say if you have any medical related query, let's say you got one disease, so you are asking for the diagnosis, you are asking for the medicine, so this bot will able to give the response with respect to that. That means it will give you the suggestion, it will give you the medicine suggestion, it will give you the diagnosis suggestion. So these kinds of information this bot will provide. So we'll be creating the complete system here. That means here first of all we'll be using our custom data. The entire, let's say, medical information custom data will be using. First of all, we'll be teaching our model, we'll be creating the entire knowledge base. Then I'm going to connect my large language model there. So that means whatever information you'll be asking related the medical, let's say any kinds of disease, any kinds of medicine, any kinds of, let's say, diagnosis. So everything your chatbot will be able to give you the response. Okay, so this is the system we'll be implementing. And this is not going to be, guys, like notebook implementation. So here we'll be creating the complete pipeline. That means we'll be creating the front end part of our application. That means we'll be creating the beautiful user interface so that user can put the query and they can get the response from the chatbot. Fine. And here we'll be using something called modular coding in Python. So it's not a like scripting programming we'll be writing. We'll be using modular concept here to implement the entire project. Fine. And also we'll be using the Git and GitHub to, let's say, do the version controlling. So that means we'll be following the entire development pipeline here. What are the things you need? Even I will also show you how we can deploy this project, okay, in a cloud platform. So everything, guys, will be implementing in this project. So make sure you're watching this video till the end. And if you have any question, you can feel free to ask me, okay, in the comment section. So first of all, what I will show you guys, I'll show you the entire project architecture, like what are the things we are going to develop. Then I will also show you the tools and technology we'll be using here. Then we'll start the implementation. Fine. So let's open up our Blackboard and try to understand the project architecture. So guys, as I already told you, we'll be using our custom data here. Okay, we'll be using custom data, custom medical data. I can write medical data. So let me show you, I'm having one entire actually medical book. So guys, you can see this is the book. The book name is the Gale Encyclopedia of Medicine. Okay, second edition. So this is the book. You can also search on Google, you will get this book. And it is having around 637 pages. It's like very big book, and it is having all kinds of information regarding the medical. So see, if you open this book, actually you will see all kinds of content. Let's say all kinds of disease, even with respect to that disease, what kinds of medicine actually you need, what kinds of diagnosis technique you need, everything this book has covered. Okay, so it is having different treatment, different actually medicine, different disease. Even the disease image is also visible here. All kinds of disease actually it is having. All kinds of disease actually it is having. Even with respect to that, they have also given a diagnosis, or even the treatment. Okay, how, let's say, you can do the diagnosis, how you can do the treatment, what kinds of medicine you have to, let's say, take. Everything this book has given the information. So here we'll be using this book, actually the entire medical information, and we'll be creating the knowledge base. That means here we'll be using Pinecone vector database. Okay, I think even the Pinecone is a cloud-based vector database. That means there we can store the embedding, vector embedding. That means first of all, we will be extracting all the information from this book. Then we'll be creating the chunks, and that chunks actually with the help of embedding model will be creating the vector embedding, and that vector embedding will be storing to the Pinecone vector DB. And that Pinecone vector DB is going to be my knowledge base. That means the entire knowledge base. Why I'm not using the local vector database here? Because my data size is huge. If you see 637 pages information I'm having. So if you just create the chunks, just try to consider how many chunks you will get. And if you're storing in the local DB, it won't be efficient. So that's why we'll be using cloud-based vector DB here. Fine. And I'll show you how we can use the Pinecone properly. It's one of the amazing vector DB when I personally prefer. So there actually you can also see your vector visualization. Okay, everything you can see. See, this is another actually disease. See, this is the disease actually. Even with respect to that, they have also given the diagnosis as well as the medicine. Now I'll share this PDF with you guys. You can see the complete book if you want to see different medicine and different let's say diagnosis. Okay, you can check it out. So here what we'll be doing, guys, we'll be using this medical book. So let's say this is one PDF documents actually I'm having, or here I can write medical. Okay, medical book. So from the medical book, what we'll do, we'll just extract all the information. Extract all docs. Okay, then after that we'll be creating different chunks, and I think you know what is chunking is required, right? Because here we'll be using large language model, and large language model is having input actually size, one specific input size, and we have to follow that input size. I think previously we learned about Llama is having 4096. Okay, this is the input length. That means this is the maximum input length it can take the data. If you're using OpenAI model also, let's say GPT. Okay, GPT is also having one specific input length. If you want to see that, just open the openai.com and go to the model section. You will see that GPT input length. So whatever actually large language model you are using, first of all, try to see the input length, okay, of that model. Like what would be the maximum token size? Based on that, try to perform the chunking operation. Okay, that should be my suggestion. Now it will give me different chunks. So let's say I will get chunk 1. Okay, chunk 1. We'll be getting chunk 2. We'll be getting chunk 3, and so on. Then after getting the chunks, what I have to do, guys, I'll be using one embedding model. Embedding model. Okay, with this embedding model, we'll generate the vector embedding. Okay, it will give me different vector embedding. So you'll be getting vector embedding. I can copy and I can paste it here. So we'll be getting different vector embedding. And with this vector embedding, guys, what we'll do, we'll just try to build one semantic index. That means the knowledge base, right? Build semantic index. So this is going to be my knowledge base. That means we'll be storing this vector to the vector database. So I can write knowledge base. Okay, knowledge base. And here we'll be using something called Pinecone vector store. Okay, so let me just write vector DB. Okay, DB vector DB. And guys, this is going to be my complete backend component. Okay, so here I can write this is going to be my backend component. Okay, component. Now I have to work on the front end component. That means user will give some query, and with respect to the query, actually I have to give the proper response. Okay, let's say this is the user. This is the user. So user will send one query. Let's say this is the query user has asked. So first of all, it will convert to the query embedding. Okay, query embedding. That means this is going to be an English text, right? And that should also convert it to the vector embedding. This vector embedding will go to the knowledge base. Okay, it will go to the knowledge base, and knowledge base will return some rank results. Okay, rank result or similarity. Let's say result it will return. Okay, rank results. So then I'll be using one large language model. So here we'll be using one large language model, LLM. So here I'm going to use OpenAI large language model. You can use any kinds of large language model. You can use open source large language model. Okay, you can also use the Gemini. You can also use let's say Mistral, anything you can use here. So here I'm going to use OpenAI large language model, because here I'm going to create a production ready application. So this application will be also deploying in the cloud platform. Okay, that's why I'll be using OpenAI model. Okay, why OpenAI model? Because OpenAI model is already hosted in the OpenAI server. We can access this model through API request. But if I'm using any open source large language model, we have to download this model in our local machine. And local machine doesn't have like good configuration, let's say instance. Let's say you don't have good configuration GPU, you don't have good configuration actually RAM, CPU. that time actually you can't execute this model in your system. Okay, it will be very much difficult for you, and you will see that inference time would be also very high. That means this model will keep processing the input. It will take lots of time to give you the response. So that's why we'll be using OpenAI model. And going forward, I'll be discussing about LLM ops, and there I will tell you how we can also use like different open source large language model. Let's say if I want to use Llama, okay, Llama. If I want to, let's say, use Mistral, Falcon, okay, Cloudy, any kinds of model if I want to use, how I can use it, even how we can use it as an efficient way, even how we can deploy these are the model in the cloud platform. So for this, we'll be using something called LLM ops. Okay, LLM ops we'll be using. That means we'll be using different platform. We'll be running about Bedrock, okay, AWS Bedrock. We'll be learning about, let's say, GCP Vertex AI. So these are the LLM ops platform. Okay, so we'll be using this LLM ops platform to access these are the model, and on top of that, we'll be creating the application. Fine. So this is what actually we'll be explaining later on, guys. So first of all, try to see how we can implement this production ready project with the help of OpenAI model. And there is another reason actually we are using OpenAI model, because if I let's say if I'm using open source large language model, you will see that open source large language model size would be very huge. Let's say around 10 GB, 20 GB. And this model you can't execute in your local machine. That means your low configuration machine. And if you're deploying this project to the cloud platform, there you have to take good instance. That means you have to take GPU based instance with higher RAM, higher CPU, higher GPU, and just try to consider about the cost, like how much cost actually it will take that cloud platform. You can go to any kinds of cloud platform, you can see their instance actually type. If you're taking GPU based instance type with higher RAM, higher, let's say, CPU, you'll see that per hour it will cost you like more amount of money. Okay, so again, you are increasing the cost here whenever you are using open source large language model. Okay, without any kinds of LLM ops tool, LLM ops platform, you will get the difficulty for sure, right? So that's why we'll be using here OpenAI model. Although it will charge you, but it will charge you less than the open source model actually will be hosting in future. Okay, this is the idea here. So now what will happen? This rank results will go to the LLM. Even this query also will go to the LLM, and LLM will process. LLM will try to understand the query as well as the rank results, whatever results actually your knowledge base is returning. Based on that, it will give you the correct response. Okay, correct response. Or you can talk about answer. Correct answer. Let's say you are asking one question. Let's say I got fever. What can I do? So it will first of all refer the knowledge base. It will try to find out the, let's say, fever diagnosis, fever medicine. Then with respect to that, it will give you the response. Got it? So this is the entire system actually will be implementing, and this is what actually our front end. So this is what actually our front end. Many people also ask me like, sir, just try to create some application with the help of good front-end development as well. So that's why I also kept this front-end development here. We'll be creating one beautiful user interface so that user can give the query here. I think you use the ChatGPT. ChatGPT is having one beautiful user interface. Okay, so we'll be also creating this kinds of chatbot kinds of interface so that user can give any kinds of query and they can get the response. Fine. So this is the entire architecture of our project, guys. Okay, I hope it is clear now. Now, technology-wise, I already told you. Here we'll be using a large language model, OpenAI. Okay, OpenAI, LLM will be using. Then here we'll be using Langchain as a generative AI framework to develop the entire project. Then here we'll be using vector database, wise Pinecone. Okay, Pinecone is a cloud-based vector database. Okay, so there actually you can create a instance and you can store your vector. And here to create the user interface, we'll be using something called Flask. Okay, Flask is a Python framework. You can create web application. Okay, with that. Got it? Yeah, so I hope these are the actually technology we'll be using as of now. And if I need it, anything, I'll tell you, okay, later on. Now, guys, what I have to do, guys, first of all, let's create one. Yeah, so let me also write, we'll be also using GitHub. Okay, GitHub to do the version controlling of our entire application. Fine. And later on, we'll be also deploying this project to the AWS cloud. Okay, AWS cloud. So we'll be learning about the simple deployment as well as the CI/CD deployment. Okay, both will be learning. So guys, this is the entire agenda. So now let's open up our GitHub and try to create one GitHub repository first of all with our project. Then we'll be starting with the implementation. Fine. So I'll go to my GitHub, guys. So this is my GitHub. You can also follow me here. I have created lots of repository that might help you a lot. So just go to the repository and here create one new repository and give the name. Let's say I want to create a medical. I'll just write end-to-end. Okay, medical chatbot, generative AI. So this is my repo name. You can give any repo name as per your requirement. Now I'll be keeping it as a public repository because I want to share this code with you so everyone can see that. I will add the readme file as well as I will add the .gitignore file. So here I'll be using Python programming. I'll be selecting the Python. Let's take the license. You can take any license. I'll be taking AMIT license. Now everything is fine. Now let's create the repository. Okay, now let's clone the repository. I'll copy the link address. Make sure you selected HTTP1. Now open up your local folder. So let me open up my local folder and here I'll open up my terminal. You can open up your, let's say git bash, you can open up your anaconda, anything, and just write the command git clone and press the link here. So it will clone that repository in your local machine. Now see, it has cloned. Now let me go inside this folder. You can see currently I'm inside Langchain project. Okay, now I want to go inside this folder. So I'll just write cd. Cd means change directory. I want to go inside end-to-end medical chatbot generative AI, this folder. Okay, now if I hit enter, you will see that I'm inside this particular folder right now. Now I'm inside this folder. Now inside this folder, I'm going to open up my VS Code. So let's open up my VS Code. So this is my VS Code, guys. Okay. Now let me zoom. Now the first thing, guys, what I have to do, I have to create one virtual environment here, because I already told you if you are creating any kinds of end-to-end project, first of all, create a virtual environment. Then you have to set up all the requirements you need here. So here, let me add all the steps you need to perform. So here I have added all the steps in the README file. First of all, you have to clone the repository. If you are using my repository, first of all, clone it, then try to create the environment with this command. So make sure you are using Python 3.10. Okay, so I'll copy the command. You can give any name. I have given LLM app. You can give any name here. Fine. So what I can do, I think use Medibot. Okay, I can use Medibot. You can use any name. Now let's create the environment. So guys, as you can see, my environment is created. Now let's activate. For this, you have to execute this command. All the command I have shared in the README file, just try to copy paste. And I will also push this code in my GitHub so that you can see the changes. Now see, medical bot has been activated. Fine. Now the next thing, we'll be creating one file called requirement.txt file. And inside that, I'll be mentioning all the requirements I need. And we'll be installing all the requirements here. So guys, here are the requirement list. So these are the requirements actually I need to implement this project. We'll be using sentence transformer, because here we'll be using open source embedding model to generate the vector embedding. So that's why we'll be using sentence transformer, and sentence transformer uses actually transformer library. That means it will use Hugging Face platform, Hugging Face hub to download that model, open source model. And with the help of that model, actually we can generate the vector embedding. And here I'm installing one specific version. You can also install the latest version, but this is the stable version I'm installing so far. Then Langchain, I think you know Langchain. Then Flask we need for the user interface. Then PyPDF, here we'll be using PDF document, that's why. Then Python.env, why? Because here we'll be managing one .env file. Okay, .env file. So inside .env file, we'll be mentioning our OpenAI credential, as well as we'll be also mentioning our Pinecone credential, because Pinecone, you also need to use one API key to authenticate with your account. Fine. Then you can see I'm installing Pinecone, and if you want to install Pinecone, you need to install this tool library, Pinecone grpc. Okay. Then you need to also install Langchain _ Pinecone. Then Langchain community, Langchain OpenAI, and Langchain experimental. Okay, so these are the dependency package you also need to install. So let me install all of them. I'll just try to save. I'll open up my README file. I'll copy the command, and here I can execute. Now see, it will install all the packages one by one. So it may take some time, guys. Let's wait. Once installation is completed, I will come back. So guys, as you can see, my installation is completed. There is no error. That means congratulations, you have installed successfully everything. Now let me minimize the screen. And now let me save everything. Yeah. Now see, whenever you are implementing any kinds of end-to-end projects, the first thing you have to create the project. Okay, project folder structure. Structure. Okay, this is very much important, guys. That means you have to create the entire project folder structure, like in which folder, in which file you have to write which function. Okay, that's how you have to create the entire project folder structure. And again, this is your actually, let's say, design pipeline. Okay, it's not like that you have to follow my pipeline always. You have to follow my project folder structure always. If you feel like, okay, this folder structure is good for you, you can use it. Just try to design with respect to your project requirement, with respect to your, let's say, choice. Okay, no need to follow my one. But if you want to follow my one, you can also follow. I usually prefer one project folder structure. Okay, so I'll be showing you how we can implement this particular project folder structure. That means automatically we'll be creating the project folder structure here. So here we'll be creating one file. So the file name is template template.py. Okay, this is going to be a Python file. So this will create the entire project template for me. So here only I need to give my one-time effort. That means I'll be writing the entire logic to create the structure. Going forward, whenever you want to create any kinds of project folder structure, you can execute this file. It will automatically create. Otherwise, what will happen? You have to manually create it. Let's say you want to create a folder. You will be clicking here. You will give the folder name. Let's say test. Okay, then I want to create another file inside folder. Again, you will be opening this folder. Inside that, you'll be creating another file. Let's say test.py. Okay. So this is like very time-taking task. Let's say you want to create 100 of folders, 100 of files. Just try to consider how much time it will take. Even you have to manually check everything, whether this file is present inside this folder or not. So it's not a efficient way to create the folder structure. Okay, you can create it, but I won't be suggesting you because it will take lots of time. So what you can do, you can create one template file. And inside template file, you can write one very Python basic code, and this code will automatically create the project folder structure for me. Let me show you how we can create it. So for this, I'm going to use some package. I'll be using operating system package. Then I also need something called pathlib. Okay, so let me import. So from it is available pathlib import. Okay, path. I need the path. Why I need the path, I'll tell you later on. As of now, let me import all of them. Then I also need something called login. Okay, so login is an inbuilt package inside Python. So here I will also log the information in my terminal. Fine. So first of all, you have to create a logging string. Okay, so basic logging configuration you have to create. So that's how you can create a basic logging configuration. See, okay, this is the basic login configuration. So here you have to write logging.basic config. Inside that, you have to mention the log label first of all. So here I am to create an information label log, and this is the format of my log. That means first of all, it will save the ASCII time. That means the current timestamp. Like let's say whenever you are executing your code, it will save that timestamp. That means the time, date. So it will save everything. Then after that, it will also save the log message, like which message you want to show. Okay, it will also save that. So whenever I'll execute the code, you will get it. Okay, what I have written here. As of now, just try to consider. You have to mention this logging string here. Fine. Okay. Now you have to give a list of the file you want to create. So let's say left hand side, I want to create some list of the folders and file. So for this, I have created a Python list. You can see. So the name of the list is list of the files. Inside that, I've mentioned I want to create a folder. You can see folder name is src. Okay, so it will create a folder here called src. Inside src, I want to create a file called init.py. That means __init__.py. And this is nothing but my constructor file. If you already familiar with OOP concept, I think you know what is constructor. So constructor is nothing but it's a special method. It's a, let's say, the magic function. It can execute automatically inside OOP. But you can also create this actually constructor as a Python file. Okay, so if you open up any kinds of end-to-end project, now let me show you. So if you go to any kinds of end-to-end repository, let's say if I open TensorFlow GitHub, it's an open source project, so I can also see their code implementation. See, they have also follow the modular approach. See, if I open any kinds of folder, let's say if I open Java folder or let's say Python folder. Now, if you just go below, you'll see this constructor file is present here. Okay, why? Because they have created so many folders. You can see so many folders, and inside that they have created different Python file. So this folder would be considered as their local package. That means they can also import some functionality from this folder. Let's say I want to import, let's say this particular function. Let's say this function, import a graph depth. What I need to do, I need to write. So what I have to write, from TensorFlow.python, okay, then dot this file and import. I want to import this function. Okay, that's how I need to import this file. That means instead of writing like all the function in just one file, what I'm doing, I'm creating a different folder. Okay, different let's say component. Inside that I'm keeping those functionality. Okay, and whenever I need it, I'll be using it later on inside my endpoint. Okay, this is called actually modular approach. And to whenever you are like following this modular approach, whenever you are creating this kinds of folder to keep your function in a file, make sure you are creating this constructor file, because this folder would be considered as your local package. Okay, because later on you have to import it. Let's say from TensorFlow.python import this function. So whenever you will be importing, make sure your Python interpreter will consider this is my local environment. Okay, that means I can import something from that folder. This is the idea. Okay, so that's why we are creating this constructor file, because src is my folder. Inside that I'll be creating one file called helper.py. Okay, and helper.py, inside helper.py, I'll be writing all the functionality. Let's say I want to ingest the data. I want to, let's say, extract the information. I want to download the Hugging Face model. All the functionality I'll be writing inside helper.py. Okay, this is the idea. Now, apart from helper.py, I need another file. So inside src, I'll be creating another file called prompt. Okay, prompt.py. Inside that, I'm going to write the prompt. Okay, prompt, whatever prompt actually I need. The prompt, let's say whatever system prompt I will be using, inside that I can write it here. Now I want to create a env file. Then I want to create a requirement.txt file. Oh, sorry, requirement is already created. I can remove it. As of now, I don't need it. I want to create a setup.py file. Why setup.py file? Because I want to install these are the folder as my local package. For this, I need setup.py. Okay. Previously, I think I already explained this part. Then app.py. Then I want to create a folder called research. Inside that, I want to create a Jupyter notebook file. That means trials.ip1b. So inside that, first of all, we'll be doing the Jupyter notebook experiment. That means the entire project will be implementing through Jupyter notebook. Then we'll try to convert everything as our modular coding. Okay, this is the idea. So this is my list of the files and folder I need. Now I have written a simple Python logic. Let me show you guys. It's not a very fancy code. It's a simple Python code I have written. So this code, it will loop through this list one by one. That means it will loop through this list one by one. See, I'm looping through the list. It will give you the file path, the entire file path. Then you are giving this path to the path function. Why you are giving to the path function? Because see, here we're using Windows machine, and Windows by default use backward slash. I think you know. See, if I click here, see, Windows by default use backward slash. But which slash actually we're using here? We are using forward slash. Okay. But in Linux, Mac actually, they will be using this forward slash. But in Windows, you have to use backward slash. So that's why to I overcome this issue, we are using path, actually path library from pathlib. See how it will work. So let me show you one example. So first of all, I will open up my Python. Okay. Now here, let me first of all import. So from pathlib, okay, import path. Okay. Then let's define a path here. So I'll just write p is equal to test, let's say slash t.py. Okay, let's say this is my folder. Inside that I'm having one file. Now what I will do, okay, it has given me one error. Let me see the error. Okay, so test is not defined. That means I need to give inside a double quotation because it's a path, not. So it should be a string type data. Now fine. Okay. Now if I give this p to my path function, now see what will happen. It will automatically detect my operating system. Based on that, it will convert that part. See, it has given me Windows path. It has automatically detected my operating system. Based on that, it will convert this path to the Windows path. Let's say you are using Linux, you are using Mac. Automatically, this path would be converted to that operating system. Okay, so that's why instead of manually giving that path as a backward slash, what I can do, I can give to the path function. Path will automatically take care. That means we can execute this project in any kinds of operating system. Okay, otherwise, in some of the operating system, you might get some issue. Okay, that's why we have to always handle this kinds of scenario. Got it? So whenever you are designing your software, make sure you are handling these kinds of scenario and you are making your application more robust. That means in production, it won't be failing. Whenever it is failing in the production, this is not a robust application. Always you need to take care. Then after that, what I'm doing, I'm just splitting my folder name as well as the file name with the help of this actually function. So inside operating system .path.split. So what path.split will do? It will split your folder name and your file name. That means inside this file directory, it will give the folder name. Inside the file name, it will give the file name only. Okay. So you can also execute and test. So let me show you. So let's say this is my path now. So this is my folder and this is my file. Now if I use, first of all, let me import operating system. So if I give os.path.split. Okay, inside that I'll give the p. Now see, if I hit enter, it will give me one tuple. See, so in the first item, it should be my folder and the second item, it should be my file. Okay. And this is what actually I'm storing inside two variable. Okay, two variable. I'm doing the tuple unpacking here. Okay, I hope it is clear. Then first of all, I have to create the folder. Okay, I have to create the folder, and to create the folder, I'm using was.make directories. So first of all, I'm checking whether this file directory, it is empty or not. If it is not empty, that means definitely I have some file folder name here. So I'm creating the folder, you can see. Then I'm performing the login operation. I'm just doing the login in my terminal. I'm creating a directory, file directory for the file of file name. Okay, this is the log message actually I'm printing in my terminal. Then after that, I'm also creating the file. That means folder creation is done. Then inside the folder, I also need to create the file. For this, I have written this code actually. First of all, I have to check whether this file path is exist or not. If it is not exist, that means if it is not created, I have to create it. Otherwise, it is already created. Now I don't need to create it. And I also check the size of the file path. That means the file, it is 0 or not. Let's see if it is not 0. That means inside that file, I have written some code. So I don't need to delete that file again. Let's say you want to create again. it won't be replacing that file. Instead of that, it will skip that file. So that's why I'm also checking the size. If size is empty, I'm creating this file, you can see, and I'm doing the login information. Otherwise, I'm telling this file is already exist. Okay, so this is the simple Python code I have written. Now see the power of this script. Okay, see the magic. Now left hand side, see, there is nothing. There is no folder structure, no file. Now if I execute this script, now see what will happen. I'll clear and I'll simply execute this template.py file. See, template.py. See, automatically it will create the folder structure for me. Got it? So it's just a one-time effort, guys. You have to like write this code only one time, and later on you can use it every time. Let's say you want to create another project, copy this file, try to execute, it will automatically create a folder structure for you. Let's say in future I need some more actually, let's say folder, or let's say file. Let's say I need another file called test.py. I'll just add it here. Make sure you are giving inside a string, okay, and you are giving a comma here because it's a list. Okay, now see, I'll execute it again. It will automatically create that for me. See, test.py is also created. That's how you can add as much as file and folder you need. Okay, it will automatically create. You don't need to manually create it here. Okay, this is the advanced ways to use this template.py file, guys. Okay, I hope it is clear. Now you can check it out. So inside resource, this trial.ip1b file is created. Now inside src, init created, helper created, prompt created. Okay, you can see init created, helper created, prompt created, .env also created, apt created, setup.py is created. Okay, everything has created. So now let's set up our project as my local package. Okay, so for this I'll be writing the setup.py code, and this is a simple code, guys. I think previously I also shared. So this is the setup.py code. First of all, give the project name. That means the package name you want to give. Let's say Generative AI project, because if I show you currently in my terminal, inside my environment, this package is not present. So I'll just write pip list. See, Generative AI project is not there. Okay, so I have to install as a Generative AI project. Okay, for this we'll be using the setup.py. Now give the version, author name, email. Okay, and find package will try to find this underscore init.py, and whenever this init.py is present, it will consider this folder as my local package. Okay, let me show you. Now to install this one, you need to give one command inside requirement.file called -e space dot. Okay, -e space dot. This is the command. Now let me save. Now let me again install the requirements. Now see, automatically it will install as my local package. Now see, one egg info file would be created here, and whenever this egg info file is created, that means this project has been set up as my local package. Let me show you. Now if I again do the pip list operation, now see, Generative AI should be there. See, Generative AI project is there. Now it is my local package. Okay, that means now I can import anything from this src itself. Got it? So this is the entire idea. Now let's commit the code in my GitHub, guys. So for this, I'm going to open up my git bash, and here I'm going to write one command called git add, then git commit -m. Now let's give one commit message. Let's say folder structure added. Then let's do the push operation. So git push origin main. Okay, now it has pushed. Now if I want to check, let's go back our GitHub. Now let's refresh. Now see, it is pushed in my GitHub, and readme is also updated. Now you can copy all the command and you can execute in your system. Okay, I hope it is clear. Great. Now the first thing, we'll be doing the notebook experiment. Okay, first of all, we'll be implementing the entire project in our Jupyter notebook. Then we'll be converting as our modular coding. And after implementing Jupyter notebook, only you just need to copy paste operation. Okay, that's it. Now, first of all, let me select the kernel. So I already created one environment called medibot. Okay, so let's select it. Now let's test whether this is working or not. So I'll give one print statement. Let's say print okay. So this notebook should work. Now it is telling just try to install some IP1B kernel package. So let me install, because I'm using Jupyter notebook inside my VS Code. For this, you need some additional package, and it will automatically install for you. So it will take some time. After that, you will see that execution would be completed. So let's wait. Okay, guys. So as you can see, execution is completed and it is giving me okay message. Okay, it's fine. Now, one thing I just wanted to show you. Let's say if I show you my project working directory right now, let's say pwd. So I'm inside this resource folder. Okay, inside resource folder. But I want to load my data, and that my data would be present inside my data folder. Let's say I'll create a folder for data. Okay, inside that I'm going to move the PDF I'm having. Let me move quickly. So guys, as you can see inside data folder, I'm having the PDF. Okay, PDF document. Now see, whenever you are implementing any project, make sure you are working in the project directory. Okay, that means your root project directory. So this is my root project directory, but currently I'm inside this resource folder. But if I want to get back, okay, inside my project working directory, so what I have to do, I have to execute one more command. So let me import operating system package. Inside operating system, you are having something called change directory. Okay, let me show you. So os.chdr, that means change directory to hire one folder back. So for this, you can write // okay, // means, so // means it will get back one folder back. Okay, let me show you. Now if I execute, now if I again show you the pwd project working directory, now see I'm inside my root project folder itself. Okay, so that's how actually you can check the folder location first of all. Okay, otherwise what will happen, you will get like path issue. Sometimes you'll get, let's say, data not found and so on. Okay, so that to prevent this issue, actually make sure you are working in the project folder directory always. Okay, this is the suggestion I want to give you. So first of all, let's import some of the library here. So here I'm importing Langchain. From Langchain, actually I'm importing PyPDF loader and directory loader, because I have told you I will be using PDF documents, and to load the PDF documents I need this PyPDF loader. It is present inside a directory. Okay, that's why I have given directory loader. Then I also need to perform chunking operation, and to perform the chunking operation I can use recursive character text splitter. Okay, I think you're already familiar with these other thing. Now let me import all of them. Now here to load the PDF, here I have written a function. Let me show you. So this is the function I have written, guys. Okay, extract the data from the PDF itself. So the function name is load PDF. It will take the actually data directory. Okay, data directory, and it will only load the PDF documents. Okay, it will only load the PDF document. Let's say you want to load the docs document, txt document. At that time, you can give the extension here. Fine. So with the PyPDF loader, it will extract the information from the PDF itself. Okay, and whatever let's say information it will extract, it will give me as a documents. Okay, you can see. Now let me show you. Let me execute. So it will return me extracted data. So here I've given the path. Okay, so it should be data. Okay, data directory. Now let me show you. So if I execute, now see it is extracting all the information from the PDF itself, and it is having almost 700 actually pages. So it will take some time. So let's wait. So guys, as you can see, my extraction is done. Now if I show you the extracted data, see this is the entire extracted data actually we got. Okay, from all the pages, it will show you the data. Now let me comment it as of now. Now what I have to do, I have to perform the chunking operation, because you remember, see the architecture, I have extracted the documents. Now I have to perform the chunking operation. Okay, and to perform the chunking operation, I will be using recursive text splitter. So with that, I have created another function here. So split the data into text chunks. So it will take the extracted data, it will perform the chunking operation. You can see. So here is the code. So chunk size is 500 and chunk overlay is 20 I have given, and it will perform the chunking operation and it will give you the chunk results. Okay, now let me show you. So now if I execute the function and if I show you the length of the text chunks, now see, you got 7020 chunks here, guys. 7020 chunks you got. Just try to see how much data actually you have in the PDF. Okay, and this is enough information to create one medical chatbot. I believe that. Fine. That's why I have taken this big data, guys. Now see, this is the entire chunks actually I got. Now what I have to do, I have to use one embedding model to like perform the vector embedding, and this embedding I'll be storing to the knowledge base, that means inside my Pinecone vector database. Okay, so now let's download one embedding model from the Hugging Face. Okay, so here is the function I have written, guys. Download Hugging Face embedding model. Now for this, I need to import this package first of all. Let me import. So this is the package, guys, Hugging Face embedding. I'm importing from the Langchain embedding. Okay, now let me execute. Now this function will automatically download one embedding model. See, this is the embedding model I want to use. Let me show you this embedding model. So this is present inside Hugging Face. So the name of the model is All Mini LM L6V2. So this is one actually embedding model, and it will give you vector dimensional 384 dimensional vector actually it will return you. And this dimension you need because whenever you are using Pinecone vector database, you need to also mention the dimension of the vector, like what is your vector dimension. Whenever you are creating the cluster, now whenever you are creating the index, that time you have to mention this dimension. So that's why always try to remember, whenever you are using Pinecone vector database, try to see what kinds of, let's say, embedding model you are using, and that embedding model returns what kinds of dimensional vector. Just try to see the documentation, you will also already get it. Fine. Now let me download the embedding model. So let me execute this function. I'll download the embedding model. See, it is downloading from the Hugging Face hub, so it will take some time. Let's wait. So guys, you can see my model has downloaded. Okay, now let's test the model. whether it is able to convert my sentence to vector embedding or not. So for this, I've given one sentence here, hello world, and there is a function called embed query. So it will automatically give you the vector embedding. And I'm also checking the length, whether it is giving me 384 dimensional vector or not. Now see, if I execute the program, now see, length is 384. And if you want to see the vector, see, this is the complete vector actually you got. Okay, I hope it is clear. Now let me comment this line as of now. Got it. Now what I have to do, guys, I have to initialize my Pinecone. Inside Pinecone, actually I have to store, these are the vector. Okay, the complete vector actually I'll be generating from my text chunks. So for this, let's open up my Pinecone. So if you want to open up the Pinecone, just write pinecone.io. So this is the website, and make sure you created one account, guys. Just do the sign up operation with your email address. You can create an account. So for me, I already have one account. Let me log in. So guys, as you can see, this is my Pinecone website. Okay, this is the interface of the Pinecone, and this is one of the amazing vector database provider, guys. You will be loving a lot. Even I personally like it. So here, what I have to do, guys, I have to create a index. That means I have to create a cluster. In that cluster, actually, I'll be saving all of my vector. They have also given the quick start, like how we can set up the Pinecone, how we can, let's say, store the data. See, all the code example they have also given. Okay, so we'll be following the same approach to store our embeddings to the Pinecone. But before that, you have to collect one API key. So how to collect the API key? Left hand side, you can see one API key option is there. Just try to click here. For me, I already created one API key. If you don't have, just try to create an API key. Just give the name. Let's say I'll give test, or you can give any name. Let's create the API key. Okay, so this is the API key. Now just try to copy the API key, guys, and try to mention inside this .env file. So I'll open the .env file. So let me paste it here, and make sure you are giving one key name here. That means this is your Pinecone API key. Okay, that's it. And make sure you are writing this thing in a string. Got it? Now let me open up my trials.ipynb. Now what I will do, I'll just create a cluster here. So let me go back to the database, and don't share this key with anyone, guys. Otherwise they will be also able to access your account. Okay, I'll be removing it after this recording. So for you, no need to share with anyone. Now inside Pinecone, either you can manually create the index. Let's say you can click here, create index. Let's create one index. Let's say I want to create, let's say anything. You can give test. Now dimension, let's say 384. The same dimension I will give here. The dimension actually I'm getting. Cosine metrics, just keep it. You can also select different metrics, like what kinds of, let's say, similarity metrics it will apply whenever it will do the semantic search operation. I want to use cosine score. Now just keep it everything as default. You don't need to change the provider. See, AWS is the free one. If you're, let's say, sign up for the first time, you can create 1 to 2 cluster here with the help of AWS cloud provider. But if you want to take their premium subscription, that means you want to create a multiple cluster. If you want to take some more space, you can see, if you're using free plan, you will get 2 GB storage here. But if you have more than 2 GB data, that time you have to take the premium subscription. Okay, that time actually what you have to do, you have to take their plan, subscription plan. Let's say if I take this one, Google Cloud. Now see the price plan. See, this is the price plan actually they have. So with respect to that, you can also purchase their let's say machine. Okay, but as of now, I'll be using the free services only. I don't need the, let's say, premium subscription of the Pinecone. But if you are creating the actual project, if you need more spaces, that time you can do it. So I'll be selecting the AWS cloud provider, and region, just keep it everything as default. Only just need to give the name. Okay, name and the dimension. That's it. 384. Okay, now let's create the index. So this is the manual approach to create the index, guys. Okay, this is the manual approach. See, this index is getting created. It is getting initialized. And once it is initialized, see, it would be connected. Okay, see, it is now connected. Okay, now if you want to connect it, you can execute this Python code and you can insert your data. All the config code they have already given. Okay, but I don't want to create this index manually. I want to create through the Python code. So let me delete it. So if you want to delete it, just click here and try to delete the index. So you have to give the name. Okay, I'll be deleting because I will be creating through the Python code. And how to create through the Python code, guys, I think they have already given one starter code, remember? So here you can give the index name, like which index you want to create, and create index. Dimension you can give here, metrics, serverless, AWS, region. Okay, everything you can pass here. So now let's use this approach to create the index. So what I'll do, I'll go back to my VS Code, and I already prepared this code for you. So let me show you. So this is the code. Only you just need to change the API key. So let me change the API key. The API key I have collected here. Let me copy and let me change it here. Or I think I can read it from the environment only. So what I can do, I can import the environment. Just a minute. So let's import. So from .env, import load env. Okay. Then I will load the env. Now simply I'll get this Pinecone API key from my environment, and here it will save inside this variable. Now this variable actually I'll pass here. Okay, so nobody won't be able to see my API key that time. So this is the best approach, guys. You can also follow. Now you can give the index name. Let's say I'll give medical bot. Let's say this is my index name. And here you have to give the dimension. So make sure which embedding model you are using and what is the dimension size. 384. That means it's fine. 384. Keep everything as default: cosine, serverless, AWS, US East 1. Okay, no need to change anything because we are using free cluster here. Fine. Now, once you will execute this code, you will see that your index would be automatically created in the Pinecone. Let me show you. So if I execute this code now, see what will happen. So guys, execution is done. Now if I get back to my Pinecone and if I refresh it here, see, medical chatbot should be created here. Let me show you. See, medical chatbot is created. Automatically it has created. And now it is active and running. Okay. Now what I can do, I can convert our, let's say, chunks to the vector embedding, and I can store inside the Pinecone vector database. So for this, what I can do. So for this, first of all, set this Pinecone API key as your environment variable. Because whenever we'll be storing the, let's say, data to the Pinecone, so Pinecone internally looks for this API key inside the environment variable. Okay, so for this we are using operating system environ. Okay, environ, and this is the key name, guys, I'm giving, and I'm setting my Pinecone API key. Okay, whatever API key I'm loading from my .env file, so it will set inside my environment variable right now. Okay, so whenever I'll execute my Pinecone code, I don't need to like again and again pass it. Okay, again and again I don't need to pass it here. This is the advantage. Now see, to store the vector embedding, this is the code snippet you have to execute, guys. So you can see this is the code snippet. Let me comment here. Now I'm importing Langchain Pinecone import Pinecone vector store. Okay. Now inside Pinecone vector store, you have one function called from documents. So first of all, you have to give the documents. That means my text chunks. The text chunks I have created. Remember. So this is the text chunks I have created. Okay. So this text chunks you have to give. Then you have to give the index name. So what is the index name I have given, guys? I think remember this is the index name. That means this index name it is already created. That means inside this index it will store the data. Got it? So make sure you check this at the variable. Now I need to give the embedding model. So I think remember we downloaded one embedding model. Okay, from the Hugging Face app. Got it? So these three parameters you have to pass here. Now see, if I execute this line, it will convert all of my data to the vector embedding and will store to the Pinecone vector database. And how many chunks I got, guys? I think remember I got 7020 chunks. That means 7020 chunks vector would be stored inside my Pinecone. So it will take some time, guys. Let's wait. After executing this code, I'll pause the video, and once this vector will get stored in my Pinecone, I will come back again. See, let me show you. If I go to my Pinecone right now, and if you refresh the page here, see, all of the vector would be stored here. Even you can also see the count. Let me show you. See, as of now, 864, let's say, chunks has been added. Now see, 1000. Now see, you can also see the visualization of the vector. It's amazing, right? So whenever you used to use local vector DB, it was not possible to visualize our vector, but here it is possible. You can see. You can also see the score. That means semantic score. Like what is the score between this vector, and this vector. Got it? This is one amazing visualization, guys, you will get in the Pinecone. And see, this is the entire vector representation of this entire sentence. Okay, entire text. Okay, and even it is also showing the page number, in which page it is extracting the data, and what is the PDF name as well. Okay, every information you can see here. Even you can also perform the query operation. That means the way you perform the SQL query, you can also perform the query operation here manually. Everything is possible, but everything will be doing through the Python code. I'm not going to use the manual approach here. Now see the vector count, guys. So 4120 vector has been stored. Now let's wait. Once it has saved all of my vector director, I'll come back and I'll show you. So guys, as you can see, my execution is completed. Now if I get back to my Pinecone and if I refresh, see, all of the vector it has stored here, like more than 7000 vector it has stored inside my Pinecone index. Okay, now what I can do, I can use this index as my knowledge base. That means we'll be connecting my large language model with this knowledge base and will be asking the query, and it will do the semantic search operation here. Okay, this is the idea. Now let's get back to my code editor. Now see, I already created the index and I already stored my vector there. Now I want to load my existing, okay, existing index. If you want to load the existing index, what you can do, you can use this code snippet. Okay, see, again I'm importing Pinecone vector register from Langchain Pinecone, and there is another function called from existing index. Okay, from existing index, you have to give the index name. So the index name, I've given the same index name, and you have to pass the embedding model. The embedding model you have downloaded. Now see, if you execute this line of code, it will load the index. That means whatever index you have created and all the vector actually it will load, and it will give you the doc source object. Okay, this is an object, doc source object. Now you can also perform the retrieve operation here. That means you can perform the similarity search operation here. Let me show you one example. There's a doc source as retriever, search type similarity, search keyword 3. That means it will give you 3 relevant answer. Let me show you. So if I initialize my retriever object, and now I will ask one question here. So this is my medical data. I will ask, let's say, what is acne? Okay, acne. So I think you know, inside this PDF, I'm having acne related disease also. Let me show you. So if I press Ctrl F, acne. So guys, as you can see, this is the acne disease. What is acne and all? So you can see acne and acne related actually treatment, okay, medicine. They have suggested each and everything. So I'll asking one question here. So what is acne? So it should give me the relevant answer, okay, for the acne from my knowledge base. Now let me execute and let me show you. Now see, if I show you this retrieved docs, it will give you 3 results actually. 3 results. Even it is also showing the source, okay, from where it has referred. Now see, different actually acne related response it has given me. Okay, because I have set search keyword is equal to 3, it will only give me 3 response. Okay, but I don't need this kinds of output. I need a complete let's say definition. Okay, what is acne? Got it? So for this, what I have to do, guys, I think you remember I have to integrate my large language model. That means here we'll be working on, user will give the answer query. This query will go to knowledge base will give the rank results. I'll be using the large language model. So LLM will process this rank results as well as the query, and it will give me the correct response. Okay, so for this, let's initialize my model. So I already told you we'll be using OpenAI model. So OpenAI, so let's initialize my OpenAI model, and I think you already know what is temperature and max token. So it is giving me one error. Okay, it is giving me error because I haven't set my OpenAI API key. So let's set the OpenAI API key. I'll open up my environment. So here is my API key, guys. So make sure you create one API key and just try to paste here. And similar wise, I also need to set this API key as in my environment variable. Okay, so let me execute this code. So here what I can do, I can duplicate this line, and here I can write OpenAI API key. So it will also give me my OpenAI API key. Then here, whenever I'm setting as an environment, here I can also change OpenAI API key, OpenAI API key. Okay, now let's set this one. Okay, string expected none time. Okay, so I think I have to load it again, then I have to execute. Now it should work. Now it is working fine. Now if I get back here, now if I initialize it, it should work. See, successfully I have initialized my large language model. Now I have to create the complete chain. For this, let's import some library. Previously I showed you now how to create the RAG application. There I think you remember we were importing this library, create retrieval chain, create stub document chain, okay, create prompt, chat prompt template, okay, everything I already showed you there. So we are importing the same code here. Now this is going to be my system prompt. So here I want to give this prompt in my language model, okay, large language model. Now I'm going to create the complete prompt template. You can see this is the system prompt, and whatever input user will give, that means the input actually I have given, it will come here and it will give you the complete output. Now let me initialize. Now let's create my chain. So create a stub chain. Inside that you have to give the LLM as well as the prompt, and whatever object you will get inside create retrieval chain, you have to pass it as well as the retriever. That means your vector store. The vector store you created, okay, retriever object. Now let's initialize my chain. Now let's ask the question. So here I will give what is acne. Okay, what is acne? Sorry, acne. Now see the response, guys. See, acne is a common skin disease characterized by pimples on the face, chest, and back. It is caused by clogged pores and become inflamed due to the oil, dead skin cells, okay, and bacteria treatment, and so on. See, that means it has given me the correct response. If you open the PDF now, this book right now, and if you read it here, you'll see that it has given me the correct response. Now see, if I giving any other question which is not relevant about the PDF, what will happen? See, now see, if I give any other, let's say, question, let's say I have given what is stats, that means what is statistics, it is telling me I don't know, because here I have given the prompt now. So if you're not getting the context, that means here this question I'm asking, this is out of context. That means the data I have given to my model, okay, the knowledge base I have given to my model, so this information is not available here. So that's why it is telling I don't know. Okay, so this is the complete custom system we have created, like custom chatbot we have created, which is only referring our custom data. Okay, I hope it is clear. So guys, this is the actually entire demo. Like that's how actually we'll be implementing the entire application. Now you can ask any kinds of question. Let me show you. So you can take any other disease. Let me show you. Or let's take any other disease. Okay, let's take this disease actually. This one. I'll copy and I'll come back here. Then I'll ask here. Now let's see. See, it is giving you the response. Growth hormones resulting the abnormal growth. Okay. See, that means this is the correct response actually I'm getting. Now, if you see the image, so the same thing. Okay. So you can see this disease is a abnormal releases particular chemical from the so blah blah blah. Okay, so you can read it. So that means we are getting the correct response. Fine. Now let's try to convert this project as our end-to-end implementation right now. That means we'll be also implementing the UI. But before that, I have to first of all create the modular coding. Okay. So what I'll do, guys, I will first of all open up my helper.py. Inside helper.py, whatever, let's say, utility related code I have written, let's say loading the data, then creating the chunks, then loading the embedding model, all the function I will move inside this helper.py. So let me open. So inside that, I'm going to import all of the library. See, I just copy pasted the code from my notebook only. If you open the notebook, the same code actually I'm copy pasting. And why it is giving the error? Because below you can see I have to select my environment, the correct environment. Let's say medical bot. Now this error will be disappeared. Now see all the function I'll just copy paste here. All the three function I have written now. My load PDF, then this one text split, and this one my load embedding model. So here I kept all the function, you can see, because I want to import from here. So these are the function I don't want to create inside my endpoint. Otherwise my code base would be like messy, right? That's why I am creating inside this particular file. Now let me save, and inside prompt actually what I will do, I'll give the system prompt, whatever prompt actually I have written. So here is the prompt, guys. I think you remember. I'll copy the prompt, and inside prompt.py I'm going to mention it here. Okay, so from here I'm going to open the prompt. Let's say in future you want to change the prompt, you want to give any other prompt, you can open this prompt.py, you can change here, it will reflect in your code. Okay, no need to open your actual code implementation that time. Fine. So let me close this at the tab. As of now it's not required. Now yeah, so helper is fine. Now what I will do, I will create another file here and I will name it as store underscore index .py. Okay, .py. Why? Because let's say you want to update this book, let's say you want to add some more information. That time again you have to store all the embeddings to the knowledge base, that means inside your Pinecone, yes or no, right? And to store it, I again need to execute one like endpoint, that means store underscore index.py. Whenever you will execute it, it will load the new information and it will store to the vector database again. Fine. So for this, what I will do, I'll prepare this one. So see, whatever code I have written now here, that means I extracted my let's say documents, I created the chunks, downloaded the embedding model. After that, I pushed everything to my vector database. Okay, see all the let's say vector database code I have written, everything I need to write inside that one. So let me import all of the library. So you can see I'm importing from src helper, that means from src helper. So inside helper I'm having three functions: load PDF, then text split, and download face embeddings. Okay, see I'm importing all of them, Hugging Face embedding. Okay, then I'm also importing Pinecone, then Pinecone vector store, then load env and operating system. First of all, I have to set my environment variable. That means my credential. Okay, Pinecone API credential. Then I will be loading my data, extracting the data, creating the chunks. Then I'll be loading the embedding model. See, load file. That means I'm loading the data. So I have to give the data location. So this is my data location. Then text splitter will run. Then download the embedding model. Okay. Then after that, I will initialize my Pinecone code base. The same code, guys. If you open the Jupyter notebook file, the same code. See, Pinecone initialization. It will create the medical chatbot. Okay. Medical bot. That means this bot it will create. Okay. Then it will actually create the index. Then it will store the embeddings. Okay. So at the very first time, you have to execute this line, guys. Okay. Very first time, you have to execute this file. Then whatever actually, let's say data you are having, it will do the vector conversion. That means embedding conversion. Then it will store to the vector database. Okay. Now what I'll do, I'll just delete my previous embeddings, whatever I created. This cluster, I want to delete it because now I'm doing the modular coding now. So I'll be executing everything from my modular coding itself. Now let me remove it. Now see, it will delete it. After some times, you will see that it won't be visible here. Now see, make sure, guys, before launching your application, first of all, you need to execute this stored_index.py. Make sure this index should be created. Otherwise, you won't be able to do the query operation, right? So at the very first time, you have to execute this stored_index.py. Okay, then you will be launching your application. That means app.py. And this one you have to only execute one time, not multiple time. Multiple time when you will be executing, whenever you will update the data. Let's say you want to add any other data, one more PDF. That time you will be executing this file. Okay. Otherwise, just keep it as default. That's it. Now let me save. Now I think this is deleted. Now see, there is nothing. Now what I will do, let me show you how it will create everything. So I'll open up my terminal. Let me clear. Now let's execute this stored_index.py. Python stored_index.py. Now let's execute. See, again, it will perform all the operation, whatever things we have done in the Jupyter notebook. So let's wait. After sometimes you will see that your index would be created, and inside index, all the vector would be stored. So guys, as you can see, my index is created. Now if I open it up, inside that, now it will store the embeddings. One by one, all the embeddings it will save. So guys, as you can see, my execution is completed and it has stored all of my vector. Now that means my this store index is working fine. I'm successfully able to store my vector. Now let's create the endpoint. Okay, that means my main application. So user will start this application right now. So here I already told you we will be using Flask. Okay, so here I already told you we'll be using Flask here. And if I'm using Flask, I need a HTML and CSS code to create the one beautiful user interface. So I already created one HTML and CSS code for you guys. If you don't, it's completely fine. Again, I'm telling you, there are so many templates you will get over the internet. There is a website called Bootstrap. Previously, I also told you, I think Bootstrap. Okay, Bootstrap website. So from here, you will get different example. Even you can also see different template it is having. Even if you search like Chatbot, HTML, CSS, free template. You will get different actually template. See, different template. You can also download the source code. You can see code is also visible. You can also download. Even you will get some website. See, different chat template. Okay, different chat template. You can use it. Okay, it's up to you. Now, what I will do, I'll quickly just show you the HTML CSS code I have prepared. For this, I think you know, if you are using Flask, you need to create one folder here called template. Okay, templates. So inside that, you have to create a file called index.html. Okay, now let me show you my HTML code I have prepared. Or it's a chatbot. What I can do, I can name it as chat.html. Okay, chat.html. Now this is the entire HTML code, guys, I have prepared. Okay, save it. Now I need to create another folder for the CSS called static. So these are the requirement folder for the Flask. If you're using Flask inside Python, you need to create these other folder. Inside static, I'll be creating a file called style.css. Okay. Now let me also paste the CSS code I copied from the internet. Okay. So this is one basic template I created. Now, whenever I will show you my application, you will see the user interface, whatever the user interface I created. Now let me create my endpoint app.py. Now inside app.py, I'll be integrating all of the functionality I have prepared so far. So first of all, let me all the required package actually one by one. So here I'm using Flask. So I have imported Flask. From the Flask, I have imported all the required functionality, you can see. Then imported download Hugging Face embedding model. Okay, because I need the embedding object to load my vector store. I think you know that I need to load this, note this actually Pinecone index. So where is the Pinecone index? So here is the Pinecone index. So I need to load this index, and to load this index, what I need the, let's say this one, embedding object. I think remember at the last I showed you, loading existing index. Okay, I think you need it. Okay, I think remember. Fine. So that is why I have to import it. Then I'm importing, you can see Pinecone store, OpenAI, retrieval, QA. That means whatever, let's say I was loading here. These are the thing I'm loading everything. Fine. Then I also need to load my prompt. So prompt is available inside my prompt.py here. So I can import it. So simply I can import, just write prompt src dot prompt import start. That means I want to start everything inside that file. Okay, that's it. Then I also need something called operating system. So import OS. That's it. Now let me initialize my Flask. To initialize the Flask, you have to use this code. Go to the Flask documentation, you will get it. Now let's set all of my OpenAI and Pinecone environment. Okay. For this, I need to use the load in environment package. That's it. Then I will be downloading the embedding model. Then I will first of all initialize my embedding object. Then I will load my existing index from my Pinecone. So let me show you. See the same code from the notebook I copied. See. So I'm loading the existing index, medical bot. Make sure name is correct. Medical bot. Yeah, it's correct. Then it will give me the retriever object. Then I'm loading the OpenAI model. Then creating the prompt template. Then after that, I'm creating the chain. Okay. Now I have to create two routes exactly. First route would be my default route. That means user will get the interface of my application. Chat.html would be rendered. Got it. Now second route I'll be doing for the chat operation. That means user is giving any query to the chatbot. So that message actually I'll be accepting. And this message I will give to my LLM. Okay. That means you can see I'm doing the invoke operation. Okay. So same invoke operation I'm performing. Let me show you. So here is the invoke operation. Remember, okay, invoke. And whatever response I'm getting, I'm printing it as well as I'm showing in my that user interface. Okay, that's it. Now let me execute my application. So I'm running on my local host, port number 8080, debug is equal to true. That means if you change anything, it will automatically update everything. So now let me show you my application. So let's open up my terminal. So I'll just execute Python app.py. Sorry, it should be Python. Spelling is not correct. Python. Okay, now it should be running. Now see, just give the allow permission. Now see, your application is running. Now let's open up our Google Chrome. Search for localhost port number 8080. See guys, this is the interface we have created. And this is one amazing interface, guys. You can see amazing chat template we have created. Because many people have requested me just try to create one front-end part of our application as well, beautiful front-end part, and that's how we can create a beautiful front-end part. Now here you can ask any kinds of question. Let's say I will ask the same question. I'll ask what is acne. The acne is a common skin disease by characteristic by pimples on the face. Fine. Then I will ask another question. Let's say I got fever. What should I do? See, now this is the response. If you are experiencing high fever, it is important to seek the medical attention. Okay. So tell me some medicine. Now see, it is also suggesting some medicine, okay, related fever. Now you can ask any kinds of question from the, let's say, PDF itself, any kinds of disease you can ask. Let's say this is the disease I want to ask. I'll just copy. And here I'll just write what is this disease and all about. See, it has given me the response. Okay, now you can read this, PDF, and you can see that. You can ask the medicine, you can ask for the treatment, anything you can ask. So this is our chatbot, guys. This is our medical chatbot we have created. And see, it is also giving you the one beautiful user interface. Okay, it is also returning. Now what we'll do, we'll just try to also deploy this application, guys, but before that we'll be implementing some more end-to-end projects. Then after that I'll keep one dedicated end-to-end, let's say, deployment session. There I'll show you how we can deploy this at the project on the cloud platform. Okay, so yes guys, I hope you liked it, but before that what I will do, guys, I will commit this at the code in my GitHub. So you can also commit from the VS Code. Let's commit from here. I'll write updated. Let's commit. And .env file would be automatically ignored by the git ignore. Okay, because inside git ignore you have already mentioned it. .git ignore would be ignored. See, .env would be ignored. Okay, so it won't be published inside my GitHub. Now if I open up my GitHub, now if I refresh, see, all the code has been updated. Now I can write the further code, let's say, step as well in the readme file. Okay, so I have added all the step. Like after that, what you have to do, after that you can set your environment key, then run store index, then app.py, then you just need to open up your localhost. Okay, now let me commit the changes as well. So readme updated. And make sure, guys, you start this repository, all of you. Start this repository. You can also fork it so that you will have the reference. Okay, now if I refresh, now see, readme is updated, and you can see all the step I have also added. That's how you can also prepare your readme file, so that if other people is referring your, let's say, GitHub, they will be also able to set up this code, okay, in their system as well. Fine. So yes guys, this is the complete implementation. I hope you liked it. So that's how we can create any kinds of end-to-end generative AI bridge project. Fine. And no need to worry, I'll also show you the deployment. Even we will be also discussing about LLM ops. With the help of LLM ops also, will be learning how we can access any kinds of open source large language model. Okay, as a hosted open source large language model, we can use it. So yes guys, this is all about from this video. If you liked it, so please try to subscribe to the channel, try to like it, and try to share it. Video will be implementing another end-to-end project called source code analysis. So here we'll be using LangChain vector database large language model. Even I will also show you how we can create a front-end application of the entire projects. So this is going to be completely end-to-end implementation, guys. So I think in our previous video, I already showed you one end-to-end implementation. We implemented one medical chatbot. So here we'll be following the same actually process to implement this project as well. Fine. And what is source code analysis? I'll tell you. I'll show you the entire architecture diagram of this project. Then I will start the implementation. So first of all, what I will show you guys, I will show you the GitHub repository creation. After creating the GitHub repository, we'll be making all the setups. Then we'll start the implementation. So let's open up our GitHub and let's create one GitHub repository for this. So guys, as you can see, I'm inside my GitHub. So here I'm going to create a new repository, and I'm going to name it as end-to-end source code analysis generative AI. Fine. So let's keep it as public repository. I'll select the readme file, and I will also take the git ignore wise python. Then let's take the license. I'll take MIT license. Now let's create the repository. So after that, I have to clone it. So I'll copy the link address. I will open up my local folder, and here I'm going to open up my git bash. Now let's write the command git clone and paste the link. That's it. See, it has cloned the repository. Okay, now I want to go inside this repository. I'll just write cd, that means change directory, to my end-to-end, okay, source code analysis. Now I'm inside this folder. Now inside this folder, let's open up our VS Code. So let me open up my VS Code. So here is my VS Code. So guys, I think you remember the first thing, we create a virtual environment, okay, for a new project. So let's create a virtual environment. For this, you need to follow some of the commands. So let me mention in the readme file. So you can see these are the steps we have to follow. So first of all, if you're using my repository, first of all, clone it, then try to create an environment with the help of Python 3.10. So the environment name is LLM app. So for me, what I've done, guys, I already created the environment in my system. So I'll just activate the environment. But for you, if you don't have the environment, just try to create it. So let me show you my environment. I'll just write conda activate LLM app. See, it is already there for me. Okay. Now the next thing what I have to do, I have to set up the requirements of the projects. Okay. So for this, I'm going to create a file called requirement.txt. Inside that, I'm going to mention all the requirements actually I need. So you can see, guys, these are the requirement I need. I need OpenAI, TikTok, and ChromaDB. So vector DB wise, I'll be using ChromaDB. Previously, I used Pinecone. You can use any of the vector DB. It's up to you. Then Langchain, Flask. So the front end implementation wise, I'll be using Flask framework. Then Git Python. Why Git Python? I'll tell you. Whenever I'll show you the architecture diagram, this part would be clear. Then python.env just to manage my credential. Okay. And I'll be using OpenAI large language model. You can also use Gemini. You can also use open source large language model. But I told you, if you're using open source large language model, you should have good configuration machine. Okay, otherwise you won't be able to execute. And that part we'll be learning in the LLM ops, right? Now let me save everything and let me install all the requirements. So for this, you can execute this command. So let's copy the command and here I'm going to execute. See, for me, I already installed all the package. That's why it's telling requirement satisfied. But for you, it will take some time. Now, the next thing, what I do, guys, usually I create a template file. I think you remember, project template file. So templates.py. Okay. And previously I shared one template code with you. I think you remember. So I'll just copy paste the same code. So if you missed out my previous implementation, guys, please try to check the end-to-end medical chatbot implementation. So there I already explained this code. Okay, this code, how we have written and all, everything I explain in detail. Okay, see, I'm using the same code, same actually template code. Now what will happen, this code will automatically create the template for me. So I already created requirement file. I don't need it. I'll remove it as of now. Okay, now everything is fine. So now if I execute this template.py file, see, it will create my folder structure. So let's see. See, it has created the folder structure. And whatever log actually you have written, it is showing in the terminal, you can see. Okay, so my folder structure is created. Now what I will do, I think you remember, first of all, we perform the notebook experiment. That means we'll be implementing the entire projects in our Jupyter notebook. Then we'll try to convert as our modular coding. Okay, so for this, I'm going to open the resource folder. Inside that, inside resource folder, I'm having one Jupyter notebook file called trials.ipynb. So here, first of all, let's select my kernel. So this is my environment. Okay. Now let's test whether it's working or not. So give okay message here. Yeah, so everything is working fine. Now, first of all, let me show you the project architecture diagram, like what we are gonna perform here. So guys, as you can see, this is the entire project architecture. So here we'll be basically performing question answer over the code base to understand how it works. See what happens actually whenever, let's say, we implement any kinds of project. Okay, let's say previously, I think you remember, we implemented one project called end-to-end medical chatbot. And this is the code base we have created, right? This is the entire repository of our project. Now, let's say if anyone new to this field, if actually he's not able to understand this project like how I have written, let's say this person will open this project. Let's say he will open this helper.py. And now he's not able to understand what is this function actually, download Hugging Face embedding. Or let's say, what is this function, load PDF file and all. Okay, let's say anything actually he's not able to understand about the project we have implemented. He's not able to understand the code we have created, right? So what actually this application can do, so if you give this GitHub repository link to our software, my software, what it will do, it will try to first of all extract all the code from the repository. Then it will create a knowledge base. Okay, and with the help of large language model, it will try to understand what you have written. Let's see, now if you're asking any kinds of question, let's say what is SRC? Inside SRC, let's say you are having helper.py. Now, let's say you are asking, let's say what is text split function, what it does. So this model will try to read this code and it will able to give the like answer. This function does this thing. And that is how actually it is working. Okay, that means it will give you the entire explanation of the code you have created. Okay, so this is called actually source code analysis. Okay, now I think you got it. What is the project actually we are implementing? So project name is source code analysis. So basically here we'll be performing question answer operation over the code base. Okay, to understand how this code works. Okay, and this is the entire diagram you can see, guys. Let's say you are having a source code. That means a complete GitHub repository. Okay, that means the complete, let's say, end-to-end implementation. So first of all, what you have to do, you have to first of all, let's say, extract all of the source code. Okay, then you will be creating actually chunk. Okay, different chunks. For this actually we'll be using something called context aware splitting. Okay, now I think you can see here we'll be using something called context aware splitting. So here is the context aware splitting, and how context aware splitting works. So let's say this is your entire source code, and I think you know inside Python programming we use functional programming, OP programming concept, right? So let's say you have created different function. I think I told you I had created different function. Let's say this one function. Let's say this one example. def4. Let's say this is the function. Inside that you are having some code. Now after doing this context aware splitting, what it will do, it will first of all extract all of the source code, then it will create different chunks. Let's say inside this function you are having let's say 200 line of code. Okay, 200 line of code. Now let's see if your chunk size, okay, chunk size, let's say you have given or let's say I can write 20,000 lines of code. Okay, now let's see your chunk size you have defined 500. Okay, 500. That means what it will happen, 500. Okay, 500, let's say what that means 500 these kinds of actually tokens would be considered as your one chunks. Now just try to consider how many chunks it will create. It will create different chunks. Obviously, let's say this is the first chunks, this is the second chunks, this is the third chunks. Let's say it has created 3 chunks. Okay, 3 chunks it has created. Now how your model will try to understand whether these chunks, the entire chunks, so it is related to this particular function. Let's say there would be so many functions, there would be let's say thousands of functions, but how your model will understand these 3 chunks I got, this chunks is related this function, def4 function. So what context aware splitting will do, it will automatically tag. So see, it is automatically tagging. So this is the chunks of def4 function. Okay, let's see, you are having another function, let's say def test. Okay, this is the function. Inside that you have subcode. First of all, it will perform this splitting, that means chunking operation. You will get different chunk. Okay, then it will also perform the tagging operation. Let's say this is the tag of test function. That means your model will try to automatically understand now. Now your model will try to understand, okay, this chunks actually I'm getting, this is related to this particular function. Okay, so that's how actually it will understand the context. It will remember the context. Okay, this is called actually context aware splitting. And this context aware splitting we only perform whenever we are working with, let's say code. Okay, code data, because previously we work with text data. Okay, text data is a different thing and code data is a different thing. That's why you have to follow this thing. Okay, now let me clear my screen. Now see what will happen. You have to create a vector store, yes or no. You can see after actually getting all the text, okay, all the chunks, you will be using embedding model. With the embedding model you will be creating vector store, and here we'll be using something called ChromaDB. Okay, ChromaDB will be using. Okay, then this would be your knowledge base. Okay, and you'll be connecting your large language model. After that, whatever question actually user will ask, okay, let's say this is the user, whatever question user will ask, it will take this actually relevant answer as well as the question. It will try to understand. Based on that, actually it will give you the actual response. Okay, so this is the entire application we'll be creating. And again, you can see here we are implementing something called one RAG application, retrieval augmented generation. Okay, because here we are feeding our custom data wise we are using code data. Okay, our let's say source code we are using here. So I hope now it is clear. Now let's start the implementation, guys. So first of all, let's implement everything in our Jupyter notebook. Then we'll try to convert everything as our modular coding. Now let me clear my screen. Okay, so first of all, let's import all of the library I need. So here you can see I have imported all of the library actually I need in this implementation. Now the first library I'm importing called from git import repo. So I think you remember we installed one package called git python. Okay, so what is git python? Git python is nothing but this is the package like git GitHub. Okay, this is the GitHub actually package inside Python. That means with the help of this package you can clone any kinds of repository from the GitHub. Let's say the way actually cloned, I think remember we open up our terminal, we just written one command git clone, then we pasted that link, right? We pasted our repository link, I think remember. Okay, and it was able to clone this repository in my system. So now if I want to do with the help of Python programming, how we can do it? For this we'll be using this package actually git python. Okay, so with the help of that we'll be easily cloning any kinds of repository from our GitHub, because I told you now user will upload one URL. Okay, that means GitHub URL, project URL, and from the URL actually it will automatically, let's say, clone the repository, then it will extract the information, that means your code base, then it will perform the chunking operation, embedding model, store the embedding in the knowledge base, then it will connect the LLM. Okay, that's how we'll be performing the entire operation. Got it? And here I'm also importing another package called language, because here we'll be using programming language. So I'm going to use Python programming. So with the help of language, actually I'll try to use Python programming language here. Then generic loader, language parser, recursive character text splitter. Okay, so these are the actually additional package I'm also importing, and I'll tell you whenever I will be using them, I'll tell you each and everything. Okay, why I'm using it and what is the use of it. Now you can see I'm importing OpenAI embedding, because I'm going to use OpenAI embedding model. Then ChromaDB vector database, I already told you. Then we'll be creating our chain. Okay, the complete chain, and here we'll be using actually memory, conversation summary memory, because I think you remember in our Langchain series actually we learned how to create the memory. Okay, like it will remember your previous context. So with the help of this conversation summary memory, we can also create a memory buffer. Okay, so this thing actually we have imported so far. Now let me execute. Now see, it should work fine because we have installed everything. Now the next thing what I will do, guys, I'll just create a folder here. So mkdir. So this is the command to create a folder. I'll name it as test repo. Okay, test repo. Now see, if I show you my project working directory right now, so pwd project working directory, I'm inside resource folder. So inside resource folder, it will create a folder called, okay, mkdir is not recognized. Okay, so it should be mk, okay, not mac. Now it should work. See, now in the test folder, it has created one folder called test repo. Inside test repo, I'm going to clone the repository. And to clone the repository, guys, you can use this code snippet. So here I'm using this one actually, I think remember, a repo. So the repo actually I have imported from Git. So inside that, you have one function called clone from. Now you have to mention the URL, like which repository you want to clone. Let's say I want to clone this medical chatbot repository. I've given the entire link. So this is the link I have given. Just copy the link and try to mention. Here you can give any kinds of URL, any kinds of GitHub URL you can mention here. That repository would be cloned. Then after that, you have to define the path. In which path you want to clone? I want to clone inside this particular path. Okay, this folder. Now see, if I execute, it will automatically clone this repository inside the test repo folder. Let me show you. Execution done. Now inside resource test repo, see, it has cloned all the source code. See, all the source code you can see it has already cloned. Okay, amazing. Now the next thing will be loading all the codes. Okay, all the, let's say, codes, all the data from this repository itself. Okay, all the Python file will be loading. That means we'll be extracting all the source code. For this, I'm going to use this code snippet. So here is the code snippet, guys. So here I'm using generic loader from file system. So I think remember we imported this generic loader from Langchain. Okay, generic. Now here I'm giving the repo path. That means where my repo is present. Then I'm giving the globe. That means it will open. That means it will extract all the Python file. Okay, .py file. Then parser. You have to mention the language. So here it is the Python language. Okay, that's why you have to give the Python language. And parser threshold, you just keep it this particular number 500. Okay, this is the default number. You can keep it. Now it will give me the loader object. Okay. Now from the loader object, I will load the documents. Now see, it will give me the entire documents right now. If I show you, see, all the content is as extracted. Okay. Now if you want to see them, now how many documents you got, you can check the length of documents. You'll see that 7 documents actually I got. Now, if you want to see any kinds of specific, let's say, documents, you can print it. Now you can see this is the entire source code. You can see it has extracted, okay, from my repository itself. Now the next thing, guys, will be performing this context aware splitting. Okay, context aware splitting, I already told you, we'll be creating the chunks, and this particular chunks will tag with the function name. For this, we'll be using this this particular code snippet. Let me show you. This is the code snippet, guys. Recursive character test splitter you can use, and inside that you only need to mention one parameter called language is equal to language.python. So it will automatically perform the context aware splitting. That means it will tag the chunks with respect to the function. Got it? And chunk size and chunks overlap I have given. Now let me execute. Now I'll apply on top of my entire documents. Okay, document splitter, split documents. I'm passing my documents. Now it will give you the entire chunks. So let me show you. So this is the chunks I got. If you want to see the length, you can also see the length. Okay, see, this is the length of my chunks. Got it? Then next thing what I have to do, guys, I have to actually use the embedding model. Okay, to convert all my source code to the embedding representation, and I will be storing to my knowledge base, that means ChromaDB. For this, I will be using OpenAI embedding model, I think, remember. So let's set our OpenAI environment API key here. So this is my OpenAI API key. So I already created and I already set here. Now let me save. I'll go back to my notebook. Now, first of all, let's load this API key with the help of .env package. So here you can see I'm loading it. Then I will set this API key as an environment variable. Then I'm going to initialize my embedding model. Okay, OpenAI embedding model. That's it. Now let's initialize my ChromaDB. So I think you remember we imported already Chroma from Langchain here. So Chroma we already imported. You can see vector store Chroma we imported. Now inside ChromaDB, we are passing our text. That means the chunks actually I created, and the embedding model as well as the parses directory. That means it will create a directory. That means database. Okay, so instead of data, you can give database. Okay, DB. Okay, DB. So it will create a database, like local database. Inside that, it will save all of your embeddings. And ChromaDB session I have already taken in the YouTube channel. You can check it out how ChromaDB works. Okay, now let me create the vector store. Now see, DB has created. Okay, inside resource, and it is converting all the code to the embedding representation. And it is saving inside DB. Now see, it has created the local database. Okay, see. Okay. Now what I'll do, I'll just make it as, now to activate this vector DB, you have to execute this line, vector db.persist. Okay. Now I'll be initializing my large language model. So here you can use any kinds of large language model. You can also use GPT-4. I'll be using the default model like GPT 3.5 Turbo. So let's initialize my LLM. Then I'll be creating the memory. That means that history memory, conversation summary memory. You can see I'm importing this library. And inside that I'm passing my large language model. Then memory key is equal to chat history. That means it will remember my previous context. Okay. Then return message is equal to true. So this is going to be my memory object right now. Then I'll be creating my final chain. So for this you'll be using a conversation retrieval chain. Okay. Now inside that give the LLM retriever vector database. Okay. And as retriever, so search type I'm giving MMR. Keyword, it will give me 8 relevant answer, and here I've given the memory. Okay. Now this is going to be my key object right now. Now let's ask one question. So I'll prepare one question here. Question is equal to, let's say, I'll go to the test repo. Inside that I'm having src folder. Inside help part, I'm having one function, let's say download Hugging Face embedding. I'll copy this function name, and here I will ask what is download Hugging Face embedding function. Okay. Let's see whether my model is able to explain or not. So this is my question. So this question I'm going to pass inside my keyword, that means my chain. Okay. And it will give me results, and I'm going to only extract the answer, okay, from the result itself. Now let's see. So guys, you can see I got the answer. The download Hugging Face embedding function downloads the embedding from the Hugging Face model. So this is the model actually. Okay. Now see if I open it up. See, it is correctly identified this model actually we are trying to download, and which returns embedding of 304 dimensions. These embeddings are used for the processing and analyze text data into context of the application. That means correct information. Okay, amazingly it has explained this function. Now you can give any other question. So what I will do, I'll copy this question and let's ask about this function right now. Let's say I'll ask about load PDF file. Okay, this function right now. Let's see what it will give me. So I'll copy the same code. And here I can mention, I think. Now let's see. So ignore this line. Okay, this line is not required. So this is your actual response. The load PDF function loads the PDF file from a specified directory using directory loader class, which is a filter of PDF files. Then it extract the documents and return the items. Amazing, guys. So that's how you can perform the keyway operation with your code base right now. If you don't understand any kinds of code, if you don't understand any kinds of function, just try to give it here and try to ask it. So it will give you the entire explanation of your code base. Okay, this is called actually source code analysis, and this is one of the amazing project, guys. Amazing project. Got it? Now this is the actually notebook experiment. Now let's try to convert this project as our end-to-end implementation. Okay, so I'll just do the copy paste operation from my notebook only, because I think I showed you in my previous implementation I did the same thing. So now what I will do, guys, I'll open up my src folder inside help part. So whatever, let's say, code I have written, okay, then let's say individually I was loading the I was cloning the GitHub, I was extracting the data, I was performing the embedding model operation. Okay, so everything I'll just write as a function inside helper.py. Okay, so now let's do it. This is how actually I implemented, guys. So I'm importing all of the necessary library. Then first of all, I created one function called repo ingestion. It will take the repo URL and it will do the ingestion operation. That means clone operation. The same thing we are doing in our notebook only. Got it? Then second function I have written called load repo. The same code, guys. That loader, generic loader I'm using here. See, it will take the repo path and it will load the, let's say, code, and it will give you the documents after extracting. Then the third function I've written called text splitter. That means it will perform the context aware splitting. Okay, the same thing. Then it will give you the embedding model. Okay, it will first of all get the embedding model from the OpenAI. It will return you. So instead of actually writing the scripting, I've just written as a function. That's it. Now the next thing what I will do, I'll add everything inside my endpoint, which is nothing but my app.py, because app.py user will execute and they will get one user interface, and from there actually they will upload, let's say they will give the URL, they will do the QA operation. Okay, so for this actually I already told you we'll be using Flask, and for the Flask actually you need one template and a static file, I think you remember. So let me show you. I already prepared one HTML and CSS code for you. So guys, as you can see, this is the template file, and inside that I'm having my index.html, and this is the HTML code. And again, I refer the internet bootstrap website to implement this actually HTML and CSS code. If you're not aware about, it's completely fine. You can use my template as it is. Okay. Now inside static folder, I'm having the CSS. That means CSS code. Okay. That means style of our web interface and all. And to execute this style.css, I am using some JavaScript actually code. You can see this is the JavaScript code. Again, I got it from the Bootstrap website. Now see how your application will look like. I'll tell you. Before that, let me write this app.py code. So inside app.py, I'm going to import all of the library I need. So you can see I'm imported all of the library like ChromaDB, load embeddings, okay, from the SRC helper because I need the embedding model, right? Then repo ingestion, I'm also importing from the SRC. Then my chat OpenAI, okay, function, then conversation summary, okay, conversation retrieval chain. So everything you can see in the notebook, I'm importing all of them here. Now, first of all, what I have to do, I have to initialize my Flask and I will set the OpenAI environment key as my environment variable here. That's it. Okay, see. Now, first of all, I will load my embeddings, okay, from my vector database. You can see I'm loading the embedding from my vector database. So for this, before that, what I have to do, I have to first of all generate the vector embedding. Let's say if user has given the URL, so it will generate the embedding, right? It will create the embeddings and it will save inside my vector database, yes or no. So for this, I'm going to create another file called store_index.py. So previously in the medical chatbot implementation, I written the same file, I think, remember. Inside that, I was doing the actually embedding storing operation. See. So you can see repo ingestion, load URL. So I'm importing everything. I'm setting my OpenAI API key. Then load repo. That means see, user will give the URL. So this URL actually repo ingestion will load and it will load the, let's say, documents. It will perform the text splitter embedding. Then this embedding will store inside my like ChromaDB. ChromaDB will create an like local database. Inside that it will save everything. Okay, I think you remember. Now here I've commented this 2 line because I will be doing this thing with the help of user interface. That means UI. Okay, not manually actually. So that means from the app.py user will give the URL. Okay, from the user interface web application user will give the URL. This URL I will receive here. Okay, I'll receive here. Then I will execute this line of code. Okay, so that's why I've commented this line. But if you want to test what you can do, you can uncomment it and you can execute this line. You will see that it will work fine. Okay, so as of now, I've just commented out. Now let me save it. Now I'll go back to my app.py. Now let's create the LLM chain. So this is the chain. The same code I've copy pasted from my notebook, guys. I'm creating the LLM, creating the memory. After that, I'm creating the QA chain. That's it. Then I'll be creating 2 route. Then I'm going to create a route actually from my Flask. So this is the default route. First of all, it will render the index.html whenever user will open the application. Okay. Then the second route I'll be creating for the repo ingestion. So whenever user will pass the URL of the GitHub and they will submit. So what will happen? It will execute this store index.py. You can see I'm executing this command python store index.py. And if you want to execute any Python file, that means if you want to execute any command, you have to use system voice.system. You can see I've imported operating system. So voice.system and inside that just give the command, it will execute this file. That means what will happen? Whatever URL user will give. Okay. So first of all, it will perform the repo ingestion. I think you remember we created the repo ingestion function. Repo would be ingested in the repo folder. And if I go it back, now see. Now it will execute this store index.py file. That means this file. Now this code will be executed. That means it will load the repo, extract the documents, create the chunks, load the embedding model, then store all the embeddings to the knowledge base. That means inside my ChromaDB vector database. Okay. Now I think you got it. Now see, this is my second route. Now I'll be creating another last route. This is for the chat operation. That means after ingesting the data, creating the knowledge base, it will perform the chat operation. User will give the message. Okay. And if message is equal to clear, it will remove your let's say entire repository. That let's say you want to clone another repository, so your previous repository should be deleted. Okay. Otherwise, what will happen? It will take all I mean space. Okay, in my system. That's why I'm removing it. I'm doing the you can say rm.rf operation. That means it will remove it. So this is a Linux command. That's why I'm executing inside voice.system. Okay. Then after that, whatever input user is giving, I'm getting the results. I'm rendering the answer. Okay. That's it. Now let's open up my application and let me show you. Now I think this part would be clear. So I'll open up my terminal. Now let's execute my app.py. So app.py will open. It's running now. Let's go back. Now just search for localhost port number 8080. Now see, this is the interface of your application. Okay. Now here you have to give the URL. So let's say I will give this URL. I'll just give it here. Now see, I'll just send it. Now see in the backend, what will happen? It will ingest, that means it will clone this repository first of all. After that, it will create the embeddings and it will save this embedding in the vector database. Now see, internally everything is executing. If you go here, now see, repo, it is cloning as well as DB would be also created. Now let's wait and let's try to see. So guys, as you can see, my execution is done. So if execution is done, you will see this message actually, response. Okay, response. So now if I open it up, now see my repo has ingested and also my DB object is created. That means my embeddings has already stored here. Now I can perform the QA operation. For this, I'll be using this template right now. And this is the same actually chatbot template I'm using from my medical chatbot. Okay. Now here you can give any kinds of question. Let's say I'll give what is. I'll ask the same question again. So I'll open the repo src helper. Let's say we'll ask this one, download Hugging Face. Like what is this function and all about? Function. Let's see. See, this is the answer I got. The download Hugging Face embedding function responsible for downloading the embedding model from the Hugging Face called sentence this model and specify return the 384 dimensional vector. Great. Now I'll ask another question. What is this function? Let's say text split. See, text split function. See, text split function purpose is to split the extracted data into smaller text chunks. These text chunks are useful for the processing and analyzing the text in a smaller, more manageable section. Great. That means it is giving you the correct response. Now you can ask any kinds of question regarding your source code. Okay. So this is the entire implementation, guys, of our project. Yeah. So I think you liked it, guys. And in the next video, we'll see the deployment, like how we can deploy these kinds of projects, okay, to the like cloud platform. So for this actually we'll be using AWS. So in AWS, I'll show you the deployment part. So before ending the session, first of all, let me commit the changes in my GitHub. So I don't want to push the repo. Let's say this repo I don't want to push. So what I can do, see, let me show you another thing. Let's say if I give clear message here, it will remove the repo folder automatically. See, repo folder would be deleted because you have written the code here. I think remember inside helper, not helper, I think inside app.py. See here, if you give the clear, it will remove the repo folder. Okay. Now if I click here, now see, then I also don't want to push this DB objects. What I can do in the git ignore, I can mention this DB. Let's say DB would be ignored. Inside everything, just try to ignore. Now let's try to see. DB is also. Okay, another actually repo I'm having inside resource. So let me also mention resource also. Inside resource, I'm having test repo. So everything I want to ignore, as well as I want to ignore the DB as well. Now I think, okay, research spelling is not correct, so it should be like that. Okay, research. Now let me save. Now see, it is ignoring everything. Okay, now let me push the changes. So I'll just write updated, commit, and seeing the changes. Now if I get back and refresh here, see, all the source code has been updated. Now let me write the further step you can perform. So here I have added the next step, like you have to create the environment file. Inside that, just set your OpenAI API key and just run app.py and you can execute your project. Okay, that's it. Now let me also update this readme file. Readme updated. Now let's refresh here. Now see, everything is mentioned. Okay, all of the command I have shared with you.
So before starting with our chainlet discussion, first of all, I just wanted to tell you something like why we should use this chainlet. And as a data scientist, actually, what are the difficulties actually we face whenever we try to develop any kinds of application, right? So I think you have used something called Streamlit to create your this kinds of web application. Even I have already showed you how we can create end-to-end like these kinds of generative AI projects with the help of Streamlit and all. See, whenever we are using Streamlit, it's a initial interface, right? Initial demo of your application. But nowadays actually this LLM comes and people are creating lots of application on top of these kinds of LLMs. And also like there are lots of application, there are lots of product in the market right now, like ChatGPT is there, Google Bard is there, right? Then Microsoft Bing Chat is also there. So if you have seen these kinds of product, these kinds of application, so you will see like this application has like very beautiful user interface, right? So whenever, let's say I'm creating any kinds of conversational agents, okay, let's say I'm creating any kind of chatbot, so we should have one like very beautiful user interface. Otherwise user might not get interest, okay, with your application. So that is the main thing actually. And Chainlit provides actually this kinds of beautiful user interface whenever you are trying to create any kinds of conversational agents and all. So we can use this Chainlit to build this kinds of LLM app super fast. Okay, I will tell you like why it is super fast, because you will see using very short line of code will be creating these kinds of application very easily, right? But if you're using Streamlit, I think you saw we need to write some more code there. Okay, but if you're using Chainlit, so like more code doesn't required here. So only using some line of code actually will be able to complete our entire projects. Okay, so this is a like very amazing package I was exploring, and I thought let's also show you this one. So that actually whenever you are learning these kinds of large language model, generative AI, so at the end you need to build some application, right? So you can use this kinds of Chainlit package with your application. And there is another reason actually you should use this Chainlit, you should explore this Chainlit. Let's say you are building some projects for your client, so you need to submit that projects to your client. So you need to submit some good you can say output from your side, otherwise your client might not get interest. So at that time, if you're using this kinds of Chainlit interface, okay, Chainlit package to create your apps and all, so it would be very much realistic and it would be very much amazing to your client whenever they will look into your application. So that is why actually whenever you are trying to build something, you have implemented any kinds of POC and all, so at that time just try to use this kinds of Chainlit package to create your apps, so that actually you can submit some good application to your client, okay, and they will be very much happy with you, right, with your work. So guys, this is the video agenda. So first of all, I will take you through the Chainlit documentation. Then I will show you like how we can use this Chainlit, and we'll be building one basic chatbot here. So I'm going to implement one food delivery chatbot. So basically it will ask for the order, okay, it will suggest you the food, then it will ask for the location, and it will take your order and all. So these kinds of chatbot actually will be implementing. I think you have seen like Zomato, right? So we'll be building some something like Zomato. You can build anything, but this is the project actually I prepared for you, so that actually you can learn something, right? So I just wanted to like make you this thing as realistic, so that whenever you are building your own projects, okay, you will get interest. So yes guys, this is all about. Now let's start with our Chainlit discussion. So guys, as you can see, this is the Chainlit documentation, and Chainlit is nothing but Chainlit is an open source Python package that makes incredibly fast to build ChatGPT like application with your own business logic and data. As you can see, if I open ChatGPT, so here you will see it has one beautiful user interface. Okay, that's why user are more interested to use these kinds of ChatGPT kinds of application. Now let's see, if you give any kinds of message, so it will take your message, even it will reply like that. Okay, so we'll be building something like that, so it would be like ChatGPT like interface, right? Then if you see here, it has also official tutorial, so you can also visit the tutorial they have given. So from there actually you can also learn. But I will make this video very simple, so that actually you can understand each and everything. Like you don't need to go through even the documentation. I will discuss everything, whatever things actually you need to explore, okay? And apart from that, anything is left and anything you want to explore from your side, you can visit the documentation and learn, okay? Yes guys, this is the documentation, as you can see, and it has also integration with these kinds of LangChain, then AutoGen, LlamaIndex, okay? You can either use OpenAI, either use LangChain, either use LlamaIndex, anything you can use, okay? All the things has been integrated with that. So in this video, actually, I'm going to use OpenAI API. That means I'm going to use GPT 3.5 turbo model to create this application, because I just want to show you quickly. That's why I will be using this OpenAI model, because there actually I will get one API key and everything would be done for me, right? But you can also use open source large language model. I think I already taken some of the session, like how we can use Google PaLM 2 Llama, then we have Llama 2, then we have Falcon, we have Mistral 7B, anything you can use here. You can also integrate a LangChain with that. I have already showed you like lots of things with the help of LangChain and all. So you can explore this thing, right? So yes guys, this is the documentation. Now here they have already given some starter code, like how we can start with this chainlit and all. So I'll show you like how we can launch this chainlit app and all. Okay, but before that, what I need to do, I'll be creating one GitHub repository. So here's my GitHub. So let me create one GitHub repository. I'll name it as LLM app with chainlit. You can give any kinds of name. So let's keep it as public. I'll add readme file. Then git ignore wise, I'll be using Python, and license, you can take any kinds of license. So let's take MIT license. Then I will be creating my repository. Now let's clone this repository in my local machine. So I'll copy this link address and I will open my local machine, and here I'll open my terminal and just write git clone and paste this link and clone it. Okay, now I'll redirect to this folder, LLM apps with chainlit. Now I am inside this folder. Now here I will launch my VS Code. So you can use any kinds of code editor. It's completely fine. So I already opened my VS Code. Now here I'll be creating some of the like folders and file. Then we'll be doing the environment setup, because I need to install some of the libraries, like let's say chainlit I need to install, then I need to also install OpenAI and all. Okay, so let's do it and see like how we can use this kind of chainlit. So here I'm going to create one folder called src. And then inside src I'm going to create one file called underscore underscore init underscore underscore dot py. I think you already know why this constructor is needed, because I'm going to consider this src as my local package, because here I'm going to writing some of the Python file, and from that file I'll be importing some of the function and all. Okay, that's why I need to create it. I think I showed you in my end-to-end process, okay, what is the use of this. Then inside that actually I'm going to create two more file. One file I will keep my LLM model, and another file I will keep my system related configuration, or you can also talk about this prompt. Okay, you can also tell it as prompt. So prompt dot py. Yeah. Now outside I will create another file called app.py. App.py. Then I also need something called requirement.txt. So requirements.txt. Then I also need something called setup.py, because of this local package installation. Yeah, so this thing is required. Now let me just write down all the requirements actually I'm going to use. So the first requirement, actually I need something called chainlit. So chainlit, so this is the package you need to install. Then I need something called OpenAI. Then I need something called python.env. I think you know why we need this .env, because I'll be keeping my like OpenAI credential inside this .env file, and using this python.env I will read that. Yeah, then I also need something called -e space dot, because of this setup.py. Now let me create that file also, .env. So here I'm going to paste my OpenAI API key. So I already created this API key. So you can also create your own API key. Okay, don't use my one. I will just remove it after this recording. Then I need to install, these are the requirements. So for this I need to create one virtual environment. So I'll open my terminal, and here I'll just write conda create -n. Let's name it as chain, or I can give yeah, chainlit demo. This is the environment name, and Python version wise I'll be using Python 3.9 and -y. Now let's activate my environment. Now I'll be installing the requirements. So just write pip install -r requirement.txt. Okay, it's giving error because we haven't added like setup.py code here. That is why it's throwing error. So I think you remember. So this code actually we usually add inside our setup.py. So this code is responsible to find this constructor file, and it will set up that folder as my local package. Okay, and here you can check the project name, version, author name, email address, and anything, right? Now let me install them. So now I'll again execute my requirement.txt. So it may take some time. Let's wait. I'll come back when it is done. So guys, as you can see, my installation is done now. Yeah, so everything is done. Now let me select the environment I created here. So it was Chainlit demo. Yeah, that's it. Now, first of all, let's test it whether everything is fine or not. So I'll close these are the file first of all. Yeah. So I'll visit this documentation again. This Chainlit documentation, and if you click on in pure Python, so they have given one like code here. So let me just copy. So this code actually, this is the echo bot. Like if you send anything, so it will respond the same message, okay, as echo. So it's just for the testing purpose, like whether we are able to launch our Chainlit app or not, and it is working fine or not. Okay, so first of all, let me check it, everything is fine or not. Then I'll add my logic. I'll add my chatbot logic here. And here if you see, this code will remain same, and here you just need to write your logic. Okay, here we'll be writing our custom logic, and this code will remain same. Okay, and this is the echo bot currently. Now here what I need to do, I'll open my terminal, and if you visit the documentation, so they're telling first of all you need to write one command called chainlit init. Okay, first of all you need to initialize the chainlit here. So it will create one folder here called .chainlit, and inside that it will contain all the configuration. See, it has created this chainlit. Inside that it has created another toml file. This is the configuration file, and it has all the configuration. Okay, so here is the configuration. So you can change this GitHub URL and all. Okay, you can also change the project name here. So here is the project name, you can also change it. So this kinds of configuration you can change. So I'll just keep it as default, no issue with that. Then I'll again open my terminal. Again I will run one command called chainlit run app.py. Okay, now if I execute this command, so you will see it will launch one server for me, and this it is running on localhost port number 8000. So I'll give allow access, and this is the default user interface. Okay, so why this message is coming here, welcome to chainlit and all. So if you see here, it has created one md file here. Automatically it has created one .md file, like markdown file, and these are the content actually it has automatically generated. Okay, now let's see if I change anything here. So let's say I will change welcome to my bot. Okay, if I change anything here, now if I go to my app and refresh, see, it has changed. That means if you want to, let's say, print any kinds of messages, okay, whenever user will launch your application, okay, so you can customize here. So I already created this md file. I already made some customization there, because I told you I'm going to implement something called this one Zomato bot. Okay, so for this actually I created some of the content related Zomato, and again I generated these are the content with the help of ChatGPT. Okay, so let me show you like what are things I have done. So here I'll just copy paste. See, this is the content I prepared. Hello, welcome to Zomato bot, and here I'm just showing some of the item like we have pizzas, then pasta, noodles, then Asian cuisines. Okay, so these are the thing actually I have generated with the help of ChatGPT. So here you can give anything, any message, whatever you feel good, you can give it here, and whatever application you are building with respect to that, just add the content here. Now if I go back to my application and refresh it, see guys, now it has changed to this content. Okay, now let's see if I give any kinds of message here, hi, so it will give me the same response like hi. Okay, now if I open my ChatGPT, and if you just compare with the ChatGPT, okay, now see, it's looking like ChatGPT only, right? So that's why they're telling Chainlit is nothing but it's a like a open source Python package, and with the help of that you can create ChatGPT like interface, okay, ChatGPT like application. So I love this Chainlit a lot because see, only using this line of code, okay, only using this line of code, like only using just one function, we are able to launch this kinds of user interface. Now let's see if you're building any kinds of product for your client, so if you submit like that, so they will be pretty much impressed by your work, okay. So that is why actually we should always use some good user interface whenever we are delivering our application, right? Now here you can give any message like I am Bappy, so it will give you the same response, okay, because we have created the echo bot. How it is working, so let me show you. So they have created one function, and this is the decorator they are using, this chainlit decorator. So this decorator is handling everything, and again they're using async and await, because async and await is helping us to read this message, okay, real time. So it is always sensing our input, and whenever we are giving something, it is receiving, and it is also sending the message to the front end, right? So this is the like code, simple code. Now here we'll be writing our custom logic. So basically we'll be building one Zomato bot with the help of this large language model. I'll be using like OpenAI GPT 3.5 turbo, and here we'll be chatting with our bot, okay, with the help of this Chanlit. And here if you see, your app name is Chatbot currently, so you can also change this name. So I told you there is a configuration it has generated. Now if you go below, so here is the option to change the name. So by default it is Chatbot, so you can also give something called Chatbot for Zomato. Okay, now if I refresh and again refresh here, uh, I need to, I think, stop the execution. So I'll open my code. Now guys, see, this name has been changed, Chatbot for Zomato. Okay, now I can close the previous one, and again it's the EcoBot. Now guys, let's add our custom logic. So for this, first of all, I will prepare my LLM, that means large language model. So this is the file. So here, first of all, I'm going to import OpenAI. So I think you know OpenAI has been updated. Now it is latest version. So they have upgraded lots of thing. And if you visit that documentation currently, so if I go to this OpenAI, openai.com, and if I log in, so this is the documentation. Now let's go to any kinds of task and let's see how we need to import. See, this is the import, and we need to initialize this client object. Okay, but initially we just need to install import OpenAI. Okay, that's how we can do it. But now actually you need to import like that, from OpenAI import OpenAI. Okay, so this is the updated version of OpenAI, and if you see here, we need to upgrade it also. Okay, if you are using previous one, so you need to upgrade also. Okay, so this is the requirement you know always need to follow. You always need to update with the documentation, otherwise you might get some issue. Okay, so let's import OpenAI. So from OpenAI, import OpenAI. Okay, so I need to make one client object here, client OpenAI. Then here I will be initializing one function. I'll create one function, so I'll name this function as ask order. Okay, ask order. So this function will this is going to be like main function. So basically this function will give me the response whatever question actually user will ask. So it will take the message. First of all, it will take the message, then it will also take the model. So model wise I'll be using something called GPT 3.5 turbo, 3.5 3.5 turbo. So this is the model I'm going to use. You can use any kinds of model. You can use GPT-4, anything you can use here. I'll be using this model because this model charge would be a little bit less for me, so that's why. Then I will also take this temperature value. What is temperature? I think you know in LLM. Temperature is like how much randomness you want from your model. Okay, if you're giving it to 0, so that means it won't be giving any randomness. It won't be like more creative. It will give you auto, like always stick output. But if your setting is too close to 1, that means you are telling your model to take risk, and it will also generate some random output. Okay, so that's why this temperature parameter is important also. Now this is my function. Now here, they have already given like how to initialize this one. If you see here, so we need to use something called client.chatCompletion.create. So let me copy this line. I'll copy this line. Then I will open my code, and here I will add it. Now inside that, I think you saw first of all, it will take the model. Model is equal to model. Then it will also take something called masses. Okay, masses. So what is masses here? So let me show you. See, masses is nothing but it's kinds of prompt actually you are giving. Basically you are giving some like zero shot or few shot prompt here, like you are telling this is the role. Okay, role means system means like you are the role. Okay, like you as a chatbot, this is your role system, and this is the content. So you are a helpful assistant. Okay, basically it is I'm telling to my bot you are a helpful assistant. And whenever user is giving some content, okay, let's say this is the content user has given, so you also need to reply as a assistant. Okay, as you can see, this should be your answer. So that means we are giving some prompt here. Okay, we are just giving some zero shot or few shot prompt here to my LLM, so that my LLM can understand what kinds of job actually I want to perform. Okay, so I think you already learned this prompt engineering and all. Okay, so this is very much important here. So let's also define this one. So I already prepared one prompt here, so let me show you. So you can also create your custom prompt, there is no issue with that. So in this prompt.py, I'll paste it out. So this is going to be like very creative. The more good prompt you actually will give to your LLM, the more good results actually you will get. Okay, so this is the prompt actually I've developed. So system instruction, as you can see, you are a Zomato bot, an automated service to collect other orders from online restaurant. Okay, if you see here, so many like content I have written here. Like, so here I'm just trying to making my bot understand like what it is going to do exactly. And these are the actually item I also like pasted here. So if anyone is asking like for the menu, so it should return something, right? So these are the actually prompt I have developed from my side. Okay, so this prompt actually I'm going to use. Now I think you remember you need to create one format, as you can see, role as system assistant. So that's kinds of format actually you need. So for this actually I already prepared. So this is going to be the format, as you can see, message, role, system, content, and system instruction I need to import from my prompt. So here I'll just write from src dot I have LLMs. Oh no, sorry, src dot prompt. Then I need to import something called system instruction. Okay, so here is my system instruction. I'm importing this one. Now here I'm just telling role, system, and content. Okay, so here I'm giving the prompt to my LLM, as you can see. Now this message actually I will give it here. Okay, yes. Now I also need to set the temperature. So temperature is equal to temperature. Okay, now this will also return something, as you can see if you go below. So this is the response format. It will give you this kinds of format as a response. It's a JSON format response. So from here actually I will need to collect this content. Okay, if you see here, I need to collect this content. Okay, content is the response. Okay, actual response, and these are some parameter it will also give you. So if you want to like extract the content, so you can copy this. Either you can also copy this one. You can also copy this one. Okay, this one also you can copy. So let me copy this one, and I'll open my bot again, and here I'll just write return response.choice message.content. I only need the content. Okay, so this is my function I have developed. So it should be messages instead of masses. Yeah, now it's fine. So now I will write my final logic. So I'll open my app.py. So here first of all I need to import my this function ask order. So let me import. So from src dot llm import ask order. Then I also need to import something called messages. Okay, because here if you see we have also created this messages. I also need this one here. Let me save it. Then if I show you now here, if you see here, whenever I was discussing this thing, So you need to prepare this message. Okay, we have created for the system. Okay, system, that means we have given the prompt. Now I also need to create for the user. Okay, like whatever input user will give. Okay, so for this, in this list, actually, if I show you, we have a message. Okay, this is the list actually, and inside that we have a dictionary. So I need to add some more, like you can say I mean messages, as you can see, one by one. So this is for the system. Then I also need to add for the user as well. Okay, so I need to just append it. So for this, what I need to do, so I'll open my app.py, and here you can append like that. So I'll just write message.append, and here I'm just initializing my user right now, role. This is user, and this is the content. What is the content user will give? The message. Okay, the message actually will send. Okay, the message actually will send from here. So this is going to be the content. So it will store here. Okay, it will store it here. That means in this list, because we are doing the append operation, right? So once it is done, I also need to give this message. Okay, I also need to give this message to my bot. So I'll just write ask order. Inside that, it will take the messages. Okay, then it will also give me something called response. It will give it will give me something called response. Okay, now if you see here, I also need to uh, provide the response here. If I show you, I also need to give the assistant response as well. Okay, as you can see, assistant response as well. So again, I will append. So whenever I will receive the response, okay, I will extract the content. So as an assistant, actually, it will give me some response. So this response actually I am appending, because if I show you here, this response should be my content. Okay, as you can see, it is returning the content, and that content actually I am storing. Now once it is done, now I also need to send the response to my this chainlit user interface, right? So to do it, actually, if you see, by default it is sending the like echo command only. The message user is giving the same message, actually it is sending. So instead of that, actually I just need to send my response. Okay, this is the response. Actually I need to send to my front end. Done. Yes, so this is the logic only. So this is a like very easy code we have written. Now here you can also integrate your open source LLM. You can use PAM2, you can use Llama. Okay, you can also use Falcon, anything you can use. I think I already showed you how to use them. And you can also integrate Langchain with that. Okay, so if you are using open source LLM, so you can also use Langchain. Okay, with the help of Langchain, you can also do it. And the same thing you can do the return here. Okay, as a response. Now let's test it whether it's working or not. So I'll go back to my chain lead. Then I will refresh. Yeah. Now let's say if I give any message, let's say hi. So it is received hi, because I need to, I think, restart it. So I'll open my terminal, and I will close the execution. If you press Ctrl C, it will close. Now let's restart again. So I have restarted. Now here is my new one. Now let's see if I give any message hi. See, it's giving hello, welcome to Zomato, how I can assist you. So here I can give my name is Bappi, uh, and I am looking for I'm looking for something. I'm looking something for dinner. I'm looking something for dinner. Okay, now it is telling, hi Bappi, I'm here to help you find something delicious for dinner. What type of cuisines you are in mood for? We have options like pizza, pasta, then Asian cuisines, then beverages and Indian cuisines. Let me know your preferred. So I will go for Indian food. Okay, now see, it is giving great choice, Bappi. Indian cuisine is always a treat, and here is some option for the Indian menu. Now it is telling butter chicken we have with naan, and even it is also giving the cost because we have added the prompt here, I think you remember. Then chicken tikka masala rice, then palak paneer, then chana masala, vegetable biryani, samosa, lachi. So I'll give, I need this one, chicken tikka masala with rice. Okay, so I'll just write add chicken tikka masala rice in the cart. Yeah, so I have added chicken tikka masala in the cart. Is there anything else would you like to order, or this is all for you? uh no, it's fine. Okay, all right, here is the summary of your order. So chicken tikka masala, now if you see, this is the price. Now it is telling is that correct, and would you like to pick up your order or have it delivered? So I'll tell have it delivered. Delivered. Great, we have will deliver your order to you. Could you please provide me your delivery address? So I'll give some address here. So I'll tell my address. My address is this is my address. Let's give this address. Okay, so thanks for providing your address, Bappy. Your order will be delivered to 17th floor, Brigade Signature Tower. The total amount for your order, $10.99. How would you like to make the payment? We accept cash on delivery or online payment. I'll go for cash on delivery. Cash on delivery. Perfect. You can pay in cash when the delivery. Thank for the placing your order. Bappy, your chicken tikka masala with rice will be delivered shortly. If you have any other questions or need further assistance, feel free to ask. Enjoy your meal. Uh, Great. Thank you. Okay. See guys, we have implemented one amazing food delivery bot with the help of this Chainlit. And now see the interface guys. It's like very professional, very amazing, right? Very amazing. Now if you deliver this project to someone else, they will be going mad, right? Like whatever things actually you have developed, right? Now what I will do quickly, what I will do, I will just quickly commit the changes to my GitHub so that else you can get the code. So I'll just write completed commit. Done. Now if I go back to my GitHub and refresh, yeah, so you have committed. So yes guys, this was the demo of the Chainlit. I think you enjoyed this package a lot, and even I'm also enjoying this package a lot. Okay, I'm just trying to use this Chainlit package to build my LLM apps and all. And see guys, like by using some like very less line of code, actually we are able to build these kinds of awesome application, and it's like very fast, right? Now we'll try to see the deployment part, like how we can deploy these kinds of projects on the cloud platform. So I think you already know we implemented so many end-to-end projects, right? So implemented medical chatbot, then source code analysis. Then we also implemented something called Zomato chatbot, right? So different application we implemented so far. Now in this video, I'll show you how we can deploy these kinds of application on the cloud platform. That means here we'll be deploying our application on the AWS cloud. If you want to learn any other cloud deployment, it is also fine. See, the process will remain same, only the cloud functionality would be different. So I'll try to create some more video on the deployment. Like I'll also show you how we can deploy these kinds of project on the GCP cloud, on the, let's say, the Azure cloud. But first of all, let's try to see how we can deploy this project on the AWS cloud. And see, this is not going to be a simple deployment. So here we'll be doing continuous integration and continuous delivery or deployment. That means CI/CD. So I think you have heard of this particular term called CI/CD, right? So we'll be learning how we can deploy this project as a CI/CD. I think you already know how to deploy any machine learning project, deep learning project as CI/CD, but we haven't seen how we can deploy any kinds of generative AI based project as a CI/CD, right? So that's why make sure you are watching this video till the end. So here I'm going to show you each and every step you have to follow. And trust me, if you follow this step, guys, you can use this step to deploy any kinds of, let's say, generative AI based project. Okay, and this is going to be production grade deployment.
Okay, so here I'm going to use different kinds of service from the AWS. Even I'll be also using Docker. That means first of all, we'll be Dockerizing the entire source code. Then we'll be deploying this application on the cloud platform. Okay, so make sure you are watching this video till the end. So before starting the deployment, guys, first of all, let me show you what exactly we're gonna perform here. What is CI/CD exactly? Then I will also discuss, let's say, what are the tools and technology we'll be using here. What are the services we'll be using here? Then I will start with the deployment, and make sure you have the AWS account. If you don't have the AWS account, guys, so you won't be able to deploy this project. So first of all, try to create one account. If you're creating for the first time, you will get $300 free credit. Okay, and this is enough for you. So try to create an account, guys. Then you can start with the deployment with me. So let's open up our Blackboard and try to see the architecture overview. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. That's a local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud manually. You just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again, you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time. Then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application. Then you will be uploading your updated code. Then this code will reflect to the endpoint. Then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application, yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CI/CD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called CI/CD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CI/CD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue, actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing. Now whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually three famous tool actually we are having in the market right now. So people are using more this GitHub Action, because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay, so here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can let's say use Jenkins, Circle CI. These are the services as well. Fine. So yes guys, this is the complete high level architecture of our deployment. Now let's discuss what are the services actually we'll be using for the deployment. See, here the first services actually I'm going to use called Docker. So I think you already know Docker. So Docker is a containerization service. So with the help of that, you can containerize your code. That means, let's say you are having a source code, you can perform the containerization. That means it will create a Docker image for you. Okay. So this image you can, let's say, keep anywhere. Let's say you can keep in the Docker Hub. You can keep, let's say, in the ECR, that means Elastic Container Registry. From there, you can pull the image and you can execute this image. Okay. So if you are using Docker, so you won't be getting any kinds of setup issue. This is the main advantage here. Then we'll be using something called ECR here. ECR means Elastic Container Registry. So this is the service from the AWS. Okay, AWS giving this service. So here you can store any kinds of Docker image. It is the same like your Docker Hub. Okay, but it is the service from the AWS. You can store the private image there, but in Docker Hub actually all the image would be public. This is the difference only. Now we'll be using another service called EC2. Okay, EC2 is a virtual machine service from the AWS. Again, it is from the AWS. Okay, so this will give you virtual machine. There you can buy, let's say, CPU based machine, GPU based machine. Okay, so all kinds of configuration would be there. So here we are using our local computer. So there we'll be getting a cloud computer. Okay, this is the difference only. Then as a CI/CD tool, I'll be using something called GitHub Action, as I already told you. Okay, we'll be using GitHub Action for the CI/CD management. Fine. So yes guys, these are the services as of now I'm going to use. So let me show you the deployment step we'll be following. For this, what I have done guys, I think you remember we implemented one medical chatbot. This is the code, and this code would be also available in your resources section. Even you will also get this code in my GitHub. So guys, this is my GitHub profile. Just search ENTBUP in the Google, you will see my GitHub, and here I have created one repository called end-to-end medical chatbot. So I'm going to commit this code here, so you will get all the source code from this repository itself. Okay, and even I will also add the deployment step in the README file. So that is what actually I have written. You can see the entire deployment step I have written here. Now this is the CI/CD deployment we'll be following. So first of all, what I have to do, we have to let's say create a IAM user. Then we'll be creating the EC2 machine ECR. Okay, then we'll be, see, this is the deployment step as of now. Just try to follow the step I'm going to show you. First of all, we'll be building our so here, first of all, we'll be building the Docker image of our source code. That means Docker image we'll be implementing. Then we'll be pushing this Docker image to the ECR. That means Elastic Container Registry to store my Docker image. Then we'll be pulling this image from ECR in the EC2. That means we'll be pulling that image in the EC2 machine in our virtual computer. Then we'll be launching this Docker image in my EC2 machine, and from there we'll be creating an endpoint, and that endpoint user will be able to access. Okay, and these are the policy I have to give whenever I will be creating the IAM user. Fine. So this is the entire step guys I have written. Even I have also given all the command you need to execute here. Now let's start the deployment guys, but before that you just need to prepare some of the files. The first file you have to prepare the Docker file. So this file will help you to containerize entire your application. That means it will perform the Dockerization, and these are the Docker command you have to write. So I think you remember we are using Python 3.10. Okay, this Python version, that's why I have taken Python 3.10 slim busted image. Then working directory, it will create a working directory called app. Inside that it will copy all the source code. Then it will install the requirements. Okay, whatever requirements actually we are having here. Got it? Then it will execute this Python 3 app.py command. So that means my endpoint would be executed. Okay, my application would be running. And make sure before actually deployment, you just store your index. Okay, in the Pinecone. So this is the Pinecone guys. It is running, and all the vector is already stored here. You can see 7020 actually record is already stored here. So I already executed this file, I think, remember, store index. So it will create all the, let's say, vector embedding, and it will store in the Pinecone. Okay, Pinecone vector database. So in this project, I was using Pinecone, I think, remember. Okay, so this should be available here. Got it? So once it is available, now what I have to do, guys, then you can create another file called docker ignore. Inside docker ignore, you can mention like some of the file which is not required. Let's say here, this file is not required. Let's say, I think this file is not required, generative AI project.egg info. Okay, so whenever it will perform the, let's say, containerization, that means dockerization, so I don't need this folder. That time what you can do, you can mention this folder name in the docker ignore file. It is the same thing as your git ignore. So it is already mentioned inside my git ignore. That's why I haven't mentioned inside my docker ignore. Docker ignore is completely empty. As of now, I need all the file. That's why I haven't keep anything here. Now let's say if you want to ignore any kinds of file which is not required, that time you can store these other file inside docker ignore. Okay, that's the thing. Now the next things you have to create. You have to create one folder called .github. Okay, inside that you have to create one folder called workflows. Inside that you have to create one YAML file. You can give any name. Here I have given cic.yaml. Okay, now see, this is the complete YAML file. So this YAML file will help me to do the CI/CD deployment. Okay, that means here it will be using something called GitHub action. Okay, and GitHub action need this YAML file. So here all the command is already written. So first of all, you will see that it will perform continuous integration. Inside continuous integration, it will authenticate with my AWS account. Okay, then it will log in with my ECR. Then whatever, let's say, Docker image actually will be building, you will push that image to the ECR. Okay, that means Elastic Container Registry. Then your continuous deployment will start. Again, it will authenticate with AWS account. Then it will pull that, let's say, image from your ECR to EC2 machine. Then it will execute it here. And here all the environment variable I have set. You can see -e means this is the environment variable. See, AWS access key, AWS secret key. I'll tell you how to generate. These are the key. Then a Pinecone API key, OpenAI API key, everything I have set here. Okay, so these are the thing we'll be reading from the secret. Okay, GitHub secret. I'll tell you how to create the GitHub secret as well. So as of now, just try to remember this is the YAML file you have to use for the CI/CD, and this YAML file you can use as it is. No need to change anything in your other project as well. Okay, that's the thing. Now let's open up our AWS account. So guys, this is my AWS account. I already logged in with my AWS account. So here, so first of all, what you have to do, you have to create a IAM user. So let's create a IAM user. So IAM. So the first thing we'll be creating one user here. So let's create one user. I'll create a user. So let's say username is, I'll give medical bot. You can give any name, it's up to you. So let's click on next. Now you have to give policies. Okay, like what are the policy you want to give in this user? I don't want to give my entire policy. That means all the services I don't want to give the access. So I'll be giving some specific access. So access wise, I already written in the readme file. Let me show you. So these are the access I'll be providing. My EC2 container registry full access and EC2 full access. Okay, these are the thing we'll be giving. So here just search it. So this is the ECR. Okay, ECR Elastic Container Registry full service here I'm giving. So let's select. And after that, again, I can delete it. Then I'll try to copy the next service. This is the service. Okay, this is the EC2 machine service. So again, search here and select the EC2 machine and click on the next. Now see that I have given this two service. Okay, next thing, just create the user. So right hand side, you can see one button is there, create user. Just click on create user. So guys, as you can see, my user has created. Now I'll click on the user. Then here you will get one option, security credential. Just click here. Then you have to create a access key. So click on create access key, select command line interface. And I understand this above recommendation and click on the next. So there is a next button, just click on the next. Now create the access key here. Now see guys, this is your access key and secret access key. Try to download as a CSV file. So let's download. So and just keep it with you. Okay, this thing I need later on. Okay, and no need to share this key with anyone. Otherwise they will also access your AWS account. Okay, so here I'm showing because after the recording I'll delete everything. Got it? So my IAM creation is done. Now I'll go back to the home page. Now the next thing what I have to do guys, I have to create a ECR repository to store my Docker image. So let's search for ECR. So just search for ECR. That means Elastic Container Registry. Just open it up and make sure you check your region, in which region you are working. See, I'm working in Mumbai, AP South 1. If you're in other region, just try to note it down. Okay, you have to note it down, this syntax actually, AP South 1, then CS Central 1. If you're, let's say, in North Virginia, you have to give US East 1. So just try to remember these are the tag. Okay, so I'm inside Mumbai, that means AP South 1. Now I'll be creating a Elastic Container Registry. So let's create, so let's click there. Now you have to give the name. Let's say I'll give medical chatbot You can give any name, it's up to you. Everything keep it as default. Now click on next. Now see, my repo is created. Now what you have to do, just copy the URI and just try to paste it as of now here, because this thing I need later on. Just for reference, I'm saving it here. Okay. That's it. Now what I will do, I will go back again. Now the next thing I have to do, I have to create my EC2 machine. Then I have to set up, these are the requirements. Okay, that means I have to set up the Docker there. Then I will be also updating that machine. So let's create my EC2 machine right now. So search for EC2 here, EC2 instance. So this is the EC2 service. Now launch the instance. Now select the Ubuntu machine. And what you have to do, give the name of the machine. Let's say medical bot machine. You can give anything. Then see, instance type, you have to take at least 8 GB RAM. 8 GB RAM, just take 8 GB RAM. I'll be taking T2 large. Okay, this machine. And then select the key value pair. If you don't have the key value pair, you can also create it. So let's say I'll give medical. So it will create one RSA file. So guys, you can see after creating and download, it will give you one PEM file. So this PEM file you can use. Let's say if you're using any third-party tool to connect with your EC2 machine, let's say Putty or Mobile Extreme, that time you can use this PEM file. But I'm going to launch my, let's say, machine in my second tab with the help of AWS only. I don't need this PEM file. Okay. So now I'll select these two options, HTTPS and HTTP. Keep it everything as default. Configuration storage at least take, let's say, 30 GB. And launch the instance right now. So here you can see, click on view all instance. Then see, my machine is running. So if status is running, now click on the machine ID. Now here you have to connect this machine. So click on the connect button. Now I'll be selecting the EC2 connector and let's connect the machine. So it will create a new tab for me. So here I will get one terminal, black terminal. So we have to use this terminal to set up everything here. And this is the production server, guys. Okay, that's how your production server looks like. See, this is the production server. Let me zoom. Now let me clear. See, here you won't be getting any kinds of UI interface. Okay, that means the way we are using our computer, it is having UI. But in the production server, you won't be getting any kinds of UI. You have to work with the terminal always. And this is the Linux terminal I got. This is the Linux machine, guys. So that's why if you know any kinds of Linux command, it will help you a lot. Got it? So here, first of all, I have to update this machine. For this, you have to execute these at the command one by one. So let's copy all the command one by one. Okay, so this is done. Now I'll copy the next command and just try to paste here. Now give yes permission and press enter. Okay, so execution is completed. Now I have to set up the Docker in the EC2 machine. So this is the command you have to run. Copy the next one and execute. Then I will execute this one, then the last command. So we have to add the Docker in the sudo group. Okay. Now if it is running or not, so what you can do, you can execute one command, docker ---- version. So if it is showing the version, that means Docker is installed successfully. Now we have to set up our self-hosted runner. EC2 as our self-hosted runner. That means we have to connect our GitHub. Okay, you can see this is the GitHub. Now this is our project GitHub. So this GitHub I have to connect with my AWS. That means whenever user will, whenever let's say developer will push the code in the GitHub, it will automatically get updated to the AWS. Okay, AWS cloud. So for this, what I have to do, I have to go to my project. Make sure you you committed your repository in your GitHub and go to the settings. Okay, go to the settings. Now here left hand side you will see one option called action. Just click on the action, click on the runners. Now create a new self-hosted runner. Now select the Linux machine and you have to execute. These are the commands. So let's copy this command one by one and let me execute here. So it will automatically make the connection with your GitHub. Let me show you. Then the third command. Then fourth command. Now you have to go to the configuration section and copy this command and execute it here. Now see GitHub action, it will automatically connect. Now it will see it has connected to the GitHub. Now it is asking for enter the name of the runner group. I don't want to give anything, press enter. Now it is asking enter the name of the runner. So here you have to give self hyphen hosted. Okay, self hyphen hosted. This is the thing you have to give. If you're giving another thing, it won't be working. Okay, make sure you're giving self hyphen hosted. Now let's press enter. Now keep it everything default, just press enter again. Then again press enter. Now see, it is done. Now the last command we have to execute this one. And you can ignore this one, it is not required. Now see, it would be connected with my GitHub. See, connected to the GitHub, listening for the jobs. Okay. Now if I show you, if I come back and now if I go to the runners, let's say, I'll go to the runners. Now see, status should be idle. You can see it is connected. Okay. Now the next thing what I have to do, I have to set up all the GitHub secrets. Okay, now let's go back to the secret. So secret variable, click on the action. Now new repository secret. Now give the secret ID. Okay, so for the first ID I have to give AWS access key ID. Just copy and give the key name here. And where you will get the value, I think remember we downloaded one CSV file. So let me open this CSV file. I will open in a Notepad++. And this is my AWS access key ID. I'll copy. And here let me paste it. Then the next one I have to give secret access key ID, copy and create another new repository secret and give it here. And in the CSV file you will get the next one. See, it is comma separated. So before the comma this is the AWS key ID, access key ID, and after the comma this is the secret access key ID. So let me copy the secret access key ID and I will paste it here. Okay, now the next thing you have to give AWS default region. So region, I already told you I'm inside Mumbai, that means AP South 1. So I think remember, I'm inside AP South 1. See, AP South 1, you have to write it. So let's write AP hyphen South. Okay, hyphen 1, AP South 1. Let's try to check AP South 1. AP South 1. Okay, fine. Now let me add it. Now the next thing I have to add my ECR repo. So ECR repo wise, I think you remember we copied one URL. So just try to get this name only. Okay. After .com, just try to get the name and try to mention here. Then the next thing I have to set my Pinecone API key. So let's copy and add it here. And I think you remember in my .env file I had my Pinecone API key. Let's copy. And this is not available inside my GitHub. That's why I'm reading from the GitHub secret. Okay, this is the idea. Now I also need to add my OpenAI secret. Okay, that means OpenAI API key. The last one you can see OpenAI API key. Let's add it. So let's copy the OpenAI API. Here I'm going to paste it. Now let's add the secret. Okay, now see everything is added. Now let me see anything is left. No, everything I have added. Now what I have to do, I have to push the changes. Okay, but before that, let me get back to my project. Now I'll push the changes. So just try to commit. To commit, just open up your git bash and try to write this command git add space dot. Then git commit -m. Let's say CI CD edit. Then git push origin main. Now if I go back to my GitHub, now see if I refresh here, so it will start running my action. Now just go to the action. Now see my action is running. See, first of all, it is running the continuous integration. So inside continuous integration, first of all, it will authenticate with my AWS ECR, build the Docker image, push it to the ECR. Okay, everything will happen. See, automatically. It's just a one-time setup, guys. Next time, you don't need to set up it. You just need to write the code and push it to the GitHub. Automatically, it will push to the, let's say, AWS server. Okay, now see. So let's wait. Once this execution is completed, I will come back. So guys, as you can see, my continuous integration is completed. Now it is running the continuous deployment. Now what it will do, it will again authenticate with my AWS cloud and it will pull that image from the ECR to EC2 machine. And if you go to the Elastic Container Registry right now, and if you refresh here, you will see the image. Okay, see Docker image is been uploaded here. Now see, it is running the deployment. Now see, it is pulling the image. So once it is pulled, then we'll doing the port mapping. We'll create the endpoint and we can access our application. Let me show you. So guys, as you can see, my execution is completed. That means both integration and deployment is executed. If you're not getting error, that means congratulations, it's done. Now I will go back to my EC2 machine. Okay. Now here in the EC2 machine, you will get one public IP address. Just let me show you. So this is the public IP address. Just try to copy and just try to open it. Okay. Now see, if I open it up, so it won't be opening because see, my application is running on port number 8080. I think you remember. Okay, so by default port number 8080 is not set. So I have to do the port mapping. So what I have to do, I'll go back, go to the instance. This is my instance. Then I'll go to the security. Okay. Now here you will see one option called security group. Just click here. Now on top you will see edit inbound rules. Okay, just try to click here. Now I'll just add the rules. Custom TCP port number, just give 8080. Just select 000. Okay. And here you will see save rules. Okay, just click on the save rules. That's it. Okay, so rules has been added. Now I'll go to the instance again. I'll open it up. Now I'll copy the public IP address again. And here, let me paste. Now you have to give clone port number 8080. Now see, if I hit enter, my application should be running. See guys, this is my chatbot is running. Now if I give any message, let's say, what is acne? See guys, it is giving me the response. Now see, my application is live right now. So it is already deployed. Now user can use my applications. Now what you can do, you can buy a domain, okay, your custom domain, and you can publish this application to the audience. Okay. Now for the second time, let's say you changed anything in the code. Let's say you added some more function. What you have to do? Only just need to commit the changes. It will automatically get updated here. Fine. So no need to set up anything from scratch. It's just a one-time setup. Once setup is completed, just try to commit the changes, it will automatically running. Okay, now you can ask me, if I close this terminal, will it work? Yes, definitely we can close it. Let's say I will close this terminal. Now if I again go to the chatbot, if I refresh, see, still my bot is running. Okay, so that's how guys we can do the CI/CD deployment. Now let me show you how we can terminate all the instance, like whatever instance we created, if you don't want to keep it running, otherwise it will charge you, right? So what I can do, first of all, I will stop the EC2 machine I've created. So select the machine, click on the instance state and terminate. So terminate will delete it. Okay, so it will terminate and delete the instance. Then after that, I also need to delete my ECR. So let's go to the ECR. So first of all, delete the image inside that. Just write the delete command. Now try to select and delete. Okay, then what I have to do, I have to delete the then I will also delete my I'm user. Okay, the I'm user I created. User. Let's select and try to delete it. Medical chatbot I have to write here. So let me copy. And let me delete it. See, everything is deleted. Now nothing will charge you. Okay. So guys, that's how we can perform the deployment. And this is the code. You can use this code as it is. Okay. The code actually have shared. So yes, guys, this is all about, and I hope you liked it. So thanks for watching, guys. And what you need to do, guys, the next project I showed you now that this one, source code analysis, you can deploy this project with the same process. Okay. Whatever project we have created so far, you can deploy with the same process. So guys, we'll be starting with another very important concept inside generative AI called LLM ops. So I think you already heard of this name, okay, called LLM ops. So the full form is large language model operation. So those who are from machine learning and deep learning background, I think you know there is another actually concept called ML ops. So with the help of ML ops, we can perform machine learning operations. That means, let's say if you want to build any kinds of end-to-end MLDL application, you can follow some certain step. Okay, there's some certain pipeline you can follow. That means you can follow some certain pipeline to implement that particular application. And here MLOps usually help you to implement that particular pipeline, right? So similar things actually we can also apply in the generative AI. So I think we saw inside generative AI, we can use different kinds of, let's say, tools and technology. Like we can use different kinds of framework. We can use commercial large language model. We can use open source large language model. Yes or no? So commercial wise, I already told you, we can use OpenAI platform, because OpenAI gives you the model with the help of API access. That means you can create an API key. With the help of that, you can access this model in the OpenAI platform. So for this, you don't need to download the model in your system. Okay, so download you don't need to do. Let's say if you're using any low configuration system, still you can use that model. But whenever it comes to open source large language model, any kinds of foundation model, I think I showed you the entire Hugging Face platform. There we are having so many open source large language model, right? Let's say if you want to use these kinds of foundation model, because apart from OpenAI, these are the model are also good. Now this is also better. Some of the model you will see it is better than OpenAI model. Okay, now if I want to use these are the model efficiently, if I want to create a efficient application, even if I want to deploy this particular application on the cloud platform, how we can do it? Because we saw that if I'm using this kinds of model, like open source model, I have to first of all download the model in our system. And whenever I'm downloading, you should have good configuration machine, yes or no? That means you should have good GPU, good memory, good CPU. Then you will be able to execute this model. And let's say you want to fine tune these are the model. Definitely you need a very good configuration GPU. Otherwise, you won't be able to fine tune that. I think we already saw one fine tuning example of Llama 2 model. There I was fine tuning this model on top of our custom data, and I was using Google Colab. So there actually it was taking lots of time, let's say, to train only one epoch. Just try to consider. Got it? So that's why LLM ops comes into pictures. So LLM ops will gives you the flexibility to work with different kinds of foundation model. Okay, like what kinds of foundation model? I think you saw like Llama is there, Mistral is there. Okay, Gemini is there. Different large language models are available. So different foundations model are available. I already showed you in the Hugging Face platform. Okay, so if you want to use these kinds of foundation model, foundation large language model with all the flexibility, you have to use something called LLM ops. There are some LLM ops platform are available. This will give you all kinds of flexibility. You can work with these kinds of foundation model. Even it will give you all kinds of functionality. Okay, all kinds of functionality it will provide you. Only you just need to use this platform to implement your LLM powered application. I'll teach you all the platform, whatever platform actually we are having, which is like famous in the market. I'll discuss all of them one by one. Okay, no need to worry. So first of all, let's try to see why LLM ops is required. Because we saw that like what is LLM ops exactly. Now we'll try to see why LLM ops is required, why we need it exactly. For this, I'm going to open up my Blackboard and there I'm going to explain this concept. So guys, I think so far you have learned about Langchain. Okay, Langchain. Then you learn about LlamaIndex. Okay, then you also learn about open source large language model. Okay, open source LLM. Even I also taught you the OpenAI. Okay, OpenAI. And OpenAI provides actually commercial model because all the models are paid here. If you want to use them, you have to pay for that, right? And how it will charge you based on the token limit. And this will give you the API key. Okay, API key. With the help of API key, you can access this model. But apart from that, there are so many actually foundation model. I think I already discussed inside Hugging Face. Okay, Hugging Face platform like Llama was there. Okay, then Mistral was there. Then Falcon was there. Okay, then Gemini, Gemma. Okay, and so on. There are so many models. If you open the Hugging Face platform, you'll see that there are so many models are available, and these are the foundation model. And this model is pretty good, guys. If you see this model is like very powerful model. It's very powerful model. Even I already showed you some of the demo. We created some of the application with the help of open source large language model. There, I think you saw the power of the model. Yes or no, right? But I think one issue you saw whenever I was using this open source large language model, the issue was this model size is very big. Let's say if I'm considering Llama 2, just try to consider about Llama 2. So now tell me, Llama 2 having actually how many variant? I think you know Llama 2 is having 3 variant, like 7 billion parameter model. Then it is also having 13 billion parameter variant model. It is also having 70 billion parameter model. Even recently, there is another model you will see called Llama 3. Okay, Llama 3. And Llama 3 is very huge than your Llama 2. So you can open up the Hugging Face hub and there you can search for Llama 3, you will see the model. So here I already told you, if I want to use this model, actually I have to use GPU based machine, GPU based system, yes or no. And if I'm not using GPU based machine, so what will happen? I won't be able to execute this at the model. But if you see, there are so many developers, there would be so many enthusiasts, they will prefer to use this at the open source large language model. But most of them will not have the GPU based machine, okay, because it's obvious now. Because if you see nowadays, actually whatever laptop, whatever let's say system we usually buy, people usually take this actually GPU, let's say 3060, okay, Ti. So I can consider RTX, okay, RTX 3060 Ti. If you have actually less budget, then you can buy this GPU. If you have more budget, you can also buy higher configuration GPU. But there are very less people, they will buy the higher configuration GPU. Let's say who have the huge amount of earning, they will buy it. Okay. But if you have actually less budget, because see, majority of the person will have the less budget whenever they buy any kinds of system. So they will have, let's say this GPU 3060 Ti. Okay. So this GPU having actually, I think around 4 to 8 GB, I think, VRAM. Okay. VRAM it is having. Okay, now just try to consider, let's say I'm loading this Llama 2 7 billion parameter, okay, this model in this GPU. So what would be the inference time? As of now, let's try to consider, let's say it will take 5 minutes, okay, 5 minutes to give you the response. Now just try to consider, if your application is taking 5 minutes to execute only one prompt, will people use your application? Tell me. If let's say I'm using ChatGPT, and if I'm giving any prompt to the ChatGPT and ChatGPT is taking, let's say 5 minutes to give me that response, so will I use the ChatGPT again? No, definitely I will not use, because nowadays you will see that people will have very less time. They want actually quick response from any kinds of application. So what you have to do, the system you are developing, this should be very fast. Okay, the inference time would be very fast here. Otherwise, people won't be using your application, right? Then let's say you are loading this 13 billion parameter model, okay, in the RTX 3060 Ti GPU. Let's say now it is taking 10 minutes to execute. Okay, 10 minutes to execute. And after that, let's say you are taking 70 billion parameter model in the RTX 3060 Ti, and you will see that sometimes it will give you memory, okay, memory out of space, okay, out of space error, okay, because this GPU doesn't have the capacity to load this 7 billion parameter model, because I told you it is having 4 GB and 8 GB VRAM. Okay, so that time actually we are not able to use this kinds of foundation model. But let's say somehow we are using this foundation model. Let's say we are using small variant of the model, let's say 70 billion or 13 billion. But what is happening? Inference time is very high here. Okay, it is like very slow here. So again, people won't be using my application. So this is another issue. Got it? Now let's say somehow you created one application. Let's say it is taking 5 minutes to execute. Now what you have to do? If you want to publish this application to the audience, you have to deploy this project, yes or no? Let's say you want to do the deployment. You want to do the deployment. Okay, deployment. Now I think previously I showed you one deployment, right? We deployed one end-to-end medical chatbot project. There I was using actually AWS. Okay, AWS. So I was using, let's say, EC2 service from there. EC2. Then I was using ECR. Okay, Elastic Container Registry. Then I was also using something called Docker. Okay, so these are the services actually I was using there one by one. Now see, there I was actually deploying the OpenAI based application. That means I was using OpenAI model. That's why I was able to deploy this project in the cloud platform with the help of these are the simple service only. But whenever you are using open source large language model, so that means this model you have downloaded in your local machine, and now what you have to do, you have to move this model to the production server, that means your cloud machine. And there, just try to consider, if you are using this kinds of 8 GB, let's say instance, like T2 large instance, will it work? So I think you remember we used something called T2 dot large instance there, and it was having 8 GB memory only. Okay, 8 GB memory with CPU code. So it won't be working, right? If I'm loading this Llama 3 or Llama 2 in this machine, it won't be working. So for this, what I have to do, I have to purchase actually a GPU based machine there. So if you see the EC2 instance, you will see that there actually will also have GPU based machine. So there actually you can also purchase GPU based machine. Apart from that, AWS provides another service called AWS SageMaker. Those who are from actually MLOps background, they already know what is AWS SageMaker. So SageMaker is a complete actually platform. So here you can actually ingest, okay, train, evaluate, okay, evaluate and deploy any kinds of machine learning or deep learning project. Okay, and it also provides different virtual instance, that means virtual computer. Okay, virtual, let's say computer, it will also give you. So there actually you can take any kinds of instance and you can, let's say, host your model. It is also possible. So SageMaker provides actually lots of service. You can search over the Google, you'll see that it provides different services. Okay, now a few months back actually I was going through one actually research article. So there I found if I want to, let's say, deploy any kinds of open source large language model, let's say my custom created, let's say, server, let's say I want to launch my own server and there I want to host my model. For this, what I can use something called SageMaker. Okay, AWS SageMaker I can use because SageMaker will give you different kinds of instance. Okay, so there actually you can host your model. And if I want to use SageMaker and if I want to, let's say, deploy these kinds of open source large language model, because see, if I want to use this kinds of open source large language model, I have to use different library. Like I told you, we have to use Hugging Face. Okay, we have to use Langchain. So different things we have to install. Even if I want to use Hugging Face, I also need to install Accelerate, Bits and Bytes, because this model access the GPU, right? And to access the GPU, I also need these are the package. Okay, I already explained in my Hugging Face session. So if I want to install these are the package, whenever, let's say I'm taking any EC2 machine, there you will see installation issue. So most of the time you will see lots of installation issue actually will get. But what they did actually, they created one service called DLC. Okay, DLC, that means deep learning container. So this service is already available in the AWS. Okay, you can use with the help of SageMaker. SageMaker, you can use this DLC, that means deep learning container. So inside deep learning container, you can install any kinds of deep learning package. Let's say you can install Hugging Face, you can install, let's say, PyTorch, TensorFlow. So all the, let's say, library would be already pre-installed there. So you don't need to, let's say, manually put the effort to install these at the library. Okay, with the GPU configuration, everything would be already there. Okay, only just need to take the DLC, let's say instance, and you have to connect with the SageMaker. That's the idea. Okay, so with the help of SageMaker, with the help of DLC, you can host this model. Let's say you are having one open source model. Now you can host this model in the DLC platform. Got it? And to get the, let's say, endpoint from the model, what you have to do, you have to use something called API gateway. Okay, API gateway. So this is another service from the AWS. With the API gateway, what you can do, you can create an API. Okay, API. Like we saw like OpenAI API. Now we used to use one API. So here also you can create an API. With the help of API, other people can access your model. Let's say this is a user. So user can access your model with the help of API request. So this API will request this, let's say, model. That means, let's say you are using Llama model. Okay, and Llama model is present inside DLC. That means deep learning container. It is running on the SageMaker actual instance. Okay, from there actually you can get the response. Now let's say somehow you deployed this a model like that. Okay, the way actually I showed you with the help of SageMaker, DLC, API gateway. Okay, all the services. Let's say you deployed this model, and now let's say it is working fine. Now there one issue we'll get. The issue is cost. Okay, so it will actually charge you huge amount of money. Let me show you. So in that research article, I got one image actually. Let me show you the image. So I have already taken the screenshot. So this is the image, guys. I think this image is visible. See what they did actually. They have taken different Llama model. You can see they have taken different Llama model. Let's say Llama 2, 7B, 7B chat, 13B, 70B. Okay. And this is the model ID and this is the max tokens. Like what would be the input length, okay, of this model? I think you know Llama 2 takes actually 4096 token. Okay. And this is the default instance type actually they are suggesting. Let's say if I want to use Llama 2 7B model. So I have to take ml.g5.2x large machine. Okay. And this machine is available in the SageMaker platform. Now let me show you the SageMaker. So if you just search for SageMaker, okay, SageMaker pricing. Just search for SageMaker pricing in Google. So you will get one website, machine learning service, Amazon SageMaker pricing AWS. Just try to open it up. Now here, if you just go below, you will see SageMaker will give you all kinds of price list with respect to all kinds of, let's say, machine type. Let's say if you want to use MLT3 medium, it is having actually 4 GB RAM, and here you will get 2 vCPU, and this is the price per hour. Like that, actually, it is having actually different instance. Actually, you can see it is also having large instance. So you can see it is also having large instance, X large instance. Okay, then 24X large also instance it is also having. Now see, the more good configuration instance you will be taking, that means your vCPU is increasing as well as the, let's say, memory is also increasing. You'll see that price is also increasing. So this is the per hour price. Let's say per hour price, it will charge you $6 if you're taking ML M5D 24X large. Now see, if I show you the chart now, so this chart also they have also suggested. Let's say you are implementing one project with the help of Llama, let's say Llama 70, okay, Llama to 70 billion parameter, and now see this is the configuration you have to take. This is the configuration you have to take. MLG5 48X large, okay, configuration machine. But let's try to consider Llama to 13 billion. Okay, let's say you want to use this actually configuration model. Now let's find this configuration. MLG5 12X large. So here you can find out that configuration. You can see there are different series are available. This is the M5, C5. You can also find out the G5. So as of now, let's try to consider this machine. Let's say ML M5D 24X large. Okay, let's say I want to use this. Okay, this machine. I want to use this machine. This machine is having 96 actually CPU, and it is also having 384 GB memory. Now, what is the per hour cost? Per hour cost is, you can see, $6. Okay, almost $6.5. You can consider $6 as of now. Now let's calculate the pricing. So what I'll do, I will open up my calculator. I'm going to actually calculate the price per day. Actually, per day, how much actually it will charge me. Let's say the price, you can see it's $6. Okay, $6 times, I want to run 24 hours. This model, okay, this model I want to run, let's say 24 hours in my actually SageMaker, okay, platform. Because see, 24 hours your application should be keep on running. It's not like that you are running for 2 hours, again you are stopping. No, people won't be using your application. ChatGPT is running 24 hours, okay, 7 days. It is all, I mean, running every time. So you will see there is no downtime. So whenever you are creating your application, it should be always running in 24 hours. Okay. So let's say I want to consider per day how much actually it will charge me. So 24, 6 times 24. So it will charge me actually $144. Only just one day it will charge me $144. Now, if you're from India, if you're from Bangladesh, if you're from any other country, just try to convert the currency, okay, in your, let's say, money, and try to see how much money actually it is taking per day from you. Got it? Now, let's say I want to run this model. Let's say I want to run this model, let's say 7 days. So what I'll do, I'll just multiply with 7. Multiply with 7. Now see, this is the 7-day cost I got, $1,008. So it is more than 1 lakh rupees. Okay, more than 1 lakh rupees actually it will take if you're running this model 7 days. Let's say I want to run this model 4 weeks. So this is the charge actually it will take. Now let's say I want to run this model 1 year. So I can multiply with 12. See, this is the 1 year cost actually you are getting. $48,000. Okay, 384. So now let's see, if you're running a small startup, if you're running a small company, so will you afford that much amount of money? Will you be able to pay this much amount of money? No, definitely you are not. So at the end, your cost is increasing. If you're using this kinds of open source large language model, if you're deploying on this kinds of, let's say, platform on the custom, let's say, hosted server, so you will have lots of cost at the end. So better to use the OpenAI model that time, yes or no? Because OpenAI model will charge you less. Very less than, okay, very less than this amount of money. Got it? So that's why actually LLM ops comes into picture. So what big tech company actually did, they came up with actually different kinds of LLM ops platform. So I think you saw, not recently actually, this LLM ops platform came actually long back. So Google actually came up with one LLM ops platform called Vertex AI. Okay, Vertex AI. So previously, when you used to use MLOps, also we used to use something called Vertex AI for the MLOps also. Because this Vertex AI provides all kinds of functionality, all kinds of, let's say, pipeline for the machine learning operation as well. Okay, nowadays they also integrated generative AI, okay, in the Vertex AI. Even AWS That means Amazon Web Service, they also came up with another LLM ops platform called Bedrock. Okay, Bedrock. Okay, Bedrock. So Bedrock is also one LLM ops platform. And this is the new service actually they have launched in the AWS, actually, let's say website. You will see that there will be one section called Bedrock. Okay, so Bedrock also provides all kinds of LLM ops services. Let's say you want to use any kinds of foundation model. You want to use Llama, Mistral, okay, any kinds of foundation model. So this model is already hosted. See, this model they have already hosted in their server. Let's say whatever Llama model, whatever Mistral model, whatever model you see, these are the model is already hosted in this LLM ops platform. Like that, Google has also hosted lots of foundation model in their server. It's not like that they're only hosting their model. Let's say Google is having their own model. They're having Gemini model. They're having Gemma model. Yes or no? Apart from these are the model, they also hosted some of the foundation model from any other organization. Let's say from Meta AI, from let's say Mistral. So what they did actually, they collaborated with these are the organization. Even they hosted their model in their platform as well. And they created one endpoint. They created one API. Okay, they created one API. Now, as a user, what I can do, I can use this API to interact with this model. That means, like our OpenAI will send the request. Okay, will send the request to this kinds of LLM ops platform with the help of API. And here I will mention what kinds of model I want to use, and this will give me the response. That means I don't need to download these are the model in my system. Okay, so this is the main benefit to use this kinds of LLM ops platform. Okay, and it is having all kinds of flexibility. Let's say you want to connect the data. You can easily connect. Let's say you want to connect the vector database. You can easily connect. Okay, that means all kinds of storage, all kinds of flexibility this LLM ops platform will provide you. It's not like that manually you have to take from any third party, let's say, tool. It's not like that. Complete, like let's say pipeline it is already having. Even let's say you are thinking to fine tune this kinds of foundation model, you can also fine tune. You can also perform the fine tune operation. So fine tuning will happening in their server only, not your system. Only you just need to set the configuration of the model. Then you have to pass your data. Automatically, it will perform the fine tuning in their server. Yeah, it is sure they will charge you, but you will see this price would be very less than your this cost actually. Whatever cost actually I showed you here. Nah? If you're let's say manually creating your server, if you're using manually different kinds of services, that time price would be high. But if you're using this kinds of LLM ops platform, your price would be very low, guys. Trust me. It would be very low. If you see the pricing, if you see the pricing, I'll tell you whenever we'll be exploring these are the LLM ops platform. There I'll also show you the pricing. You'll see the pricing, it should be very low. Alright. So that's why actually LLM ops is required. We need the LLM ops if I want to use these kinds of foundational model. It's not like that we only need to rely on the OpenAI model, because we saw that there are so many models which is more powerful than my OpenAI model. Even there is another cloud provider, I think you know, Azure. So Azure also having one LLM ops platform called Azure OpenAI. Okay, Azure OpenAI. So they have what they did actually, they collaborated with OpenAI and they bring the OpenAI platform in the Azure platform only. Okay, on top of that, they created some more services and it is running on the Azure right now. So if you know about OpenAI now, OpenAI, so you'll be also work with the Azure. Okay, Azure, let's say OpenAI. So OpenAI wise, we already saw how we can use OpenAI with the help of OpenAI API, how we can access different kinds of foundation model. Okay. So yes, guys, this is the complete idea of our LLM ops and why LLM ops is required. Okay. So in the next video, we'll be learning about one amazing actually LLM ops platform called Vertex AI from the Google side. So we'll see the entire platform, what kinds of service it provides. Even we'll also do lots of practical. We'll also do the hands-on. We'll be creating different, let's say LLM powered application with the help of Vertex AI. Even I will also show you the AWS Bedrock, how we can use the Bedrock, okay, to implement any kinds of end-to-end LLM powered application. Even we'll also learning how we can deploy these at the project as well. Fine. In this video, we'll be starting with our very first LLM ops platform called Vertex AI. And I think I already told you Vertex AI is the platform from the Google. So it is available in the Google Cloud. So Google has developed this platform. So here we'll be doing this complete generative AI on the Google Cloud. We'll be learning how we can use different kinds of foundation model. Even with that, how we can create different kinds of LLM powered application. So guys, here you can see this is the complete revolution at the Google inside artificial intelligence. I think you remember in 2017, they bring actually one architecture called transformer. So whenever this transformer architecture came in the market, after that actually so many revolution happened in the field of language model, in the field of large language model. That means whatever architecture you can see nowadays, all the architecture are using this transformer architecture in the backend. Even I already created one video, right? I already took one session on the transformer architecture, like what was the main component inside transformer architecture and why it is so powerful, right? So then after that, actually in 2018, actually they came up with another model called BART, B-E-R-T. So this is one of the actually language model they brought. Then they brought actually T5 model. Then slightly actually in 2020, actually they brought one large language model called Lambda. So Lambda was a amazing model in the field of large language model. Then 2021, they actually published AlphaFold model. Then 22 Palm model. And in 2023, they introduced something called BART model. Okay, B-A-R-D, BART. I think we used to use Google BART, right? Google BART, that means it is the ChatGPT kinds of interface, I think, remember. Nowadays, this BART has been, let's say, replaced with the Gemini. So we now actually we search for Gemini, but previously we used to search for BART, right? So this was the first application from the Google, actually they published. And you can see the model summary, like what are the tasks this model can perform. So as you can see, T5 can perform text-to-text generation. It's a transfer learning model. It is having actually 10 billion parameter and it's open source model. Then Google Lambda model. Then you can see the Lambda model trained to converse. Then AlphaFold predict structure for all known proteins. Then Palm, actually, this is the industry leading actually large language model. They introduced something called conversational AI, a service powered by Lambda. Okay. Then in 2024, I think you can see from the Google research, we are having Gemini. Then Imagen 2. Okay, this can actually generate image, okay, with respect to the text prompt. Then we're having also something called Llama. Okay, Llama is one of the large language model. Then there is another model called Sharp. This is the model, it can generate speech to text. So that's how actually revolution happened. That means it took actually lots of time to came up in this position. And Google introduced actually so many research, so many model, okay, so many technology. And nowadays actually we are using these kinds of technology, okay, in the field of generative AI. And guys, here you can see these are some actually first party foundation model like Palm for text. You can customize language task. Then Palm for actually chat. So here you can perform conversation. Okay. Then you can do the image gen. Okay. For the text to image. That means if you give any, let's say, prompt, it will generate the image. Okay. Then we also had something called embeddings model. That means embedding API. Let's say you want to generate any kinds of embedding for the text or image. You can use this kinds of embedding model. Okay. Then chart model, speech to text. Then code generation model was also available. So this was the first party foundation model in the Google research. Okay. Then they introduced something called Model Garden. Okay. So what is Model Garden? So here you can access, customize and experiment with different foundation models and its API. Okay. That means what Google did actually, they introduced one platform called Vertex AI. So Vertex AI was the platform in the Google, and it's been actually long. This platform is available in the Google Cloud, but only we used to perform MLOps operation with the help of Vertex AI. But whenever actually this generative AI came, so they updated this Vertex AI and they introduced something called Model Garden. That means inside Vertex AI, you have one Model Garden. Inside Model Garden, you are having all kinds of Google model. Whatever model actually Google has published now, all the model you will get, all the foundation model you will get in the Model Garden. Apart from that, you will also get something called open source model. Like whatever open source model I think I showed you now, from the Hugging Face, from different, let's say, organization like Llama, Mistral, Falcon, right? Different kinds of open source model I think I already introduced in the Hugging Face. So what they did actually, they also hosted this kinds of open source model in the Model Garden. That means you can use all kinds of open source model from the Model Garden itself, okay, from the Vertex AI. Then it is also having some partners model. So what is partners model exactly? So they collaborated with different kinds of organization. They collaborated with the different kinds of company. Let's say Cloud is a company. Then we are having Meta is a company. Okay, that's how we are having different kinds of company. So this company has also introduced so many large language model. Okay, so what they did actually, they collaborated with the company, collaborated with the organization, and all kinds of actually model they introduced in the Model Garden. So this is called actually partner models. Now let me show you the Vertex AI platform right now, how it looks like. You can see guys, this is the previous Vertex AI platform. Okay, that means here we used to only perform the ML operation. That means machine learning operation. That means you can perform the experiment, train and deploy. Okay, for the data science workbench. Now what they introduce actually on top of this platform, they introduce generative AI. You can see they introduce something called generative AI platform. That means here you can perform the prompt designing, fine tuning, generative AI studio, okay, foundation model, open source model. Okay, then you can also perform actually LLM ops, everything you can perform in this platform right now. That means instead of replacing the previous actually, let's say Vertex AI services, on top of that, they created one additional layer And this is called actually LLM Ops platform nowadays on the Vertex AI. Okay, now I think it is clear. Now, as I already told you, they introduced so many actually partners model. Okay, I already told you they introduced so many partners model in the model guidance. So these are the partners. Okay, these are the partners actually with Google. I think nowadays they also collaborated with so many organizations. If you open the Google Cloud Vertex AI, will see different kinds of actually partner models are available. So here you can see AI21 Labs. These are another organizations that they collaborated with the Google. Then Anthropic, Cohere, then Contextual AI, okay, Midjourney, then OSM-MO, then Resistant.ai, Meta, okay, Runway, and so on. So these are the actually partners model actually you'll be getting in the model guidance. Now let me show you this GCP, okay, GCP Vertex AI. So let's open up our account and let's open up the Vertex AI there and try to see whether these are the things are available or not. So for these guys, what you can do, just search for GCP, okay, GCP console in your Google and make sure you have one GCP account. Okay, if you don't have the GCP account, guys, so you won't be able to use the Vertex AI. So make sure if you don't have the account, just try to create one account. Initially, it will give you $300 credit. Okay, so let me log in with my console. So guys, as you can see, this is my GCP console. So here, what you have to do in the search button, just search for Vertex AI. Okay, Vertex AI. So you'll see this is the platform. This is the LLM Ops platform you will get. See, this is the complete Vertex AI. Now, left-hand side, you will see different kinds of services. So here, I already told you it is having model guidance. So let me click on the model guidance. So here, you will see all kinds of model. So guys, as you can see, whatever model I showed you, all kinds of model are available. Apart from that, they have also actually brought new model here. You can see. So foundation model, okay, then partners model. See, all kinds of models are available. Okay, as you can see, Meta model is available. That means Llama 2, Llama 3. Okay, then Palm model. You can also show all the model here. See here, I can click on the show all model. See, all kinds of model are available. See, Mistral also is there. Then Jamba model. Then you can see Cloudy. Okay. Apart from that, you will see different kinds of actually foundation model you will get. Okay. And these are the actually partner. Okay, partner company. Apart from that, you can also filter out. Let's say you need language model. So here you are having 63 language model. You can filter out all the language model. Let's say you need vision model. You are having 11 vision model. You can also filter out all the vision model. Okay. Now let's say you want to use this model. Just click here. And you will get all the guideline how to use this model and all. Okay, they have already given the source code, everything they have given. Okay, how to use the Python SDK for let's say using this model and all the let's say guideline they have already given. Okay, I'll tell you how we can use these are the model one by one. Okay, now let's say you want to also play this model in the model garden. Okay, it is also possible. Let me show you. So let's say this is my model garden. Let's say I want to let's say play with this model Gemini 1.5 Pro. So I'll just click here. Now you can see open in a Vertex AI Studio. So here you can open this model in the AI Studio. So they are also having one AI Studio. Let me show you. Even you can also open with the help of Collab Notebook, and there also you can also play with this model. Now let's click on the I agree and continue. Now here you can pass any kinds of prompt. Let's say I will give hello, and I will send this prompt. And this is the response actually I'm getting. Okay, so that's how actually you can play with different kinds of model before using it, like how this model is working on all, what is the performance of the model, everything you can perform here. Okay, then you can also search by the model name. Let's say you need Gemma model, Llama model, anything you can search here. You will also get these are the model. Got it? And guys, these are the model is already hosted in the Google Cloud, so you don't need to manually download these are the model in your system. You can use these are the model with the help of API request. As I already told you, that's how. So that is why we call it as a LLM Ops platform. Okay, so they gives the API kinds of functionality with the help of API request. We can use these are the model in our let's say project implementation. And don't you worry, I'll tell you how we can access different kinds of model. We'll be also implementing some kinds of application. Now, apart from that, Vertex AI also provides so many services. You can see it provides the pipeline services. This is the pipeline for the ML ops. Let's say you want to perform any end-to-end pipeline, data ingestion, data validation, model training, model evaluation, you can use the pipeline services. Apart from that, it also provides the notebook services. That means, let's say you want to, let's say use one large language model. You want to fine tune one large language model, you can use their Collab Enterprise. That means you can take the machine, okay, good configuration machine, good configuration Collab notebook in their Google Cloud service. Okay. Then you can also take the workbench as well. Then you can see different studio is there. You can perform different kinds of, let's say, task demo. Let's say you can perform chat demo, vision demo, translation, speech. Okay, you can play with these are the functionality. As of now, I'm not showing. Then you can also download different kinds of extension for the generative AI from the extension market. Here you will also get something called feature store dataset, okay, labeling task, then training, experiment. Okay, so some of the services you will see, these are the MLOps services, not the generative AI services. Apart from that, you will also get something called vector SARS here. This is another super important service from the Vertex AI. Let's say you don't want to use any other vector database. What you can do, you can use this Vertex AI vector SARS. This is another vector database, okay, and this is hosted in the Google Cloud. That means in the Vertex AI. So going forward, I will also show you how we can use this vector search, okay, vector search functionality from the Vertex AI itself. So yes, guys, these are the services actually Vertex AI provides. So unless and until you are not exploring all the functionality, okay, you won't be getting. So try to open this account, guys, and try to explore all kinds of functionality, okay. And now there I told you we can perform different kinds of operation, okay, different kinds of this operation. It will give you all kinds of functionality, okay. And I showed you the model garden and all. So then I already told you we can also perform something called fine tuning. So it's not like that you can only use these are the foundation model for the inference. No, you can also perform the fine tuning operation. That means this Vertex AI will give you the functionality. You can also improve the model performance with the help of fine tuning. Okay, on top of your custom data. You can also perform something called human feedback to increase your model usefulness. Like I think previously you saw in the ChatGPT, it used to give one feedback box, right? Let's say how is your experience, so that you can give your experience rating. So that kinds of rating also you can pass if you're using this kinds of Vertex AI. Then here you can also generate customized images for your business. Then here you can also improve Google's predictive AI with your own custom data. Okay, everything is possible here. Now you can ask me what kinds of tasks actually I can perform here. You can perform all kinds of tasks. So you can perform language, image, video, okay, documents, speech, tabular. So here all kinds of tasks you can perform with the help of Vertex AI. Okay. And what Vertex AI actually provides, as I already told you, it will give you state-of-the-art foundation model. Even you will also get end-to-end governance. That means you can do the prompting, tuning. Okay, you can also perform MLOps operation on the Vertex AI. Even here you will get the data privacy. So whenever, let's say, you are uploading your custom data to the Vertex AI, it's not like that your data would be leaked. It would be secure. Okay, so this kinds of actually ensured you will get if you're using a Vertex AI platform. That means you will have the complete data security. So no need to worry about your data. If you're having any custom data, all the data would be secured here. So now I think you got the difference between MLOps and LLMOps. So in the Vertex AI, we have the MLOps like services already. On top of that, they created the LLMOps. Okay. So here we don't need to throw out your existing MLOps investment. Okay. So here what you need to do, you just need to understand the unique MLOps need for the generative AI. That means whatever additional, let's say, functionality they have given, just try to understand and try to use, let's say those are the service in the generative AI field. Okay. That means you can see in the Vertex AI, you will see multitask model prompting. Okay. Then model garden, customization, managing new artifacts, evaluation, monitoring. Okay. Connecting with the enterprise data. Let's say you want to connect with different kinds of data sources. It is also possible in the Vertex AI. So now as a high level, you can see the complete MLOps on the Vertex AI. This is the, so this was actually our traditional Vertex AI. That means here we can perform experiment, training and deploy and predict, okay, for the machine learning operation. And now in the Vertex AI, you can also perform something called prompt predict. Okay, then you can also use something called foundation model. That means all kinds of generative AI based functionality you will get here. Then I already told you, you can also connect with different enterprise data. Let's say you want to connect any external sources, any API, any website, you can also connect, okay, with the help of Vertex AI. So guys, all kinds of flexibility you will get here if you're using Vertex AI LLMOps platform. So no need to worry about anything. So yes, guys, this is the complete introduction of our Vertex AI, the complete generative AI on the GCP cloud. In the next video, we'll try to see how we can build different kinds of transformative LLM powered application, okay, with the help of this Vertex AI platform. So far, we have discussed about LLM ops and this generative AI Vertex AI. Now in this video, we'll be trying to use this Vertex AI as a practical. That means, let's say if I want to use any kinds of foundation model with the help of Python code, so how we can do it. Okay, that means we'll be doing the entire hands-on in this video. So try to open up your Google Cloud, guys, everyone, and just try to open up your Vertex AI. I already showed you how we can open up the Vertex AI, right? Now, after opening the Vertex AI, the first thing you have to do, you have to enable all the recommended APIs. So there you will see one option, enable all the recommended APIs. So make sure you have already enabled all the recommended APIs. So after enabling, in the notification bar, you will see all the API has been enabled. So these are the API you should enable. Otherwise, sometimes actually will get actually different error. So that's why make sure you enable all the API. Now here you can either open up your Google Colab to perform all the, let's say, operation I'll be doing here. Either you can also open up this Colab Enterprise or Workbench. Okay, so here I'm using this cloud platform, that means LLM Ops platform. So in this video, I'll show you how we can use their services actually Let's say if I want to use Collab Enterprise, how we can use Collab Enterprise. You can also launch this Workbench. So what is the difference between Workbench and Collab Enterprise? Let me show you. So in Workbench, actually, you can select the machine configuration. So here you can create a new Workbench. Just try to click on create. Now here you can select the machine configuration, like what should be the machine name, what is the reason. Then you can also select the instance type. Okay, that's how actually you can change the configuration. Okay, all the configurations you can change here. Okay, everything you can change here. That means if you want to create a custom machine as per your requirement, you can change here. And here you can see the pricing summary. That means per hour, it will charge you $0.18. You can see price is very less. It's not like a very huge amount of money they will be charging. It's like very less money. So you can also create your custom configuration. But here I'm not going to create the custom configuration. What I'll do, I'll use the Collab Enterprise. Okay, this one. So it will give me Google Colab kinds of interface. And there I can actually do my coding. So after clicking on Collab Enterprise, so here you will get one option, create a notebook. Okay, so just create a notebook. You can also select the region, but I will keep the default region, US Central 1. Okay, that's it. Now you can give the name. I can rename this notebook. Let's say I'll rename it as Vertex AI Demo. Okay, you can give any name. I've given this name. Now, if you want to increase the size of the notebook, if you want to increase the size of the cell, let's say if I write something, so the text is like very small here. So I can also increase the size. So for this, what I can do, I can click on the settings. You just go to the editor. And here you'll see this font size. Just try to make it as, I can take 28. Okay, 28, I think it is fine. Now, the next thing what you have to do, guys, you have to connect this notebook. So let's click on the connect button. See guys, once you will be connecting the notebook, it will give you this kinds of pop-up screen. That means you have to select an account, okay, like which account you want to use. So make sure whatever actually account you are using for the Google Cloud Console, that means for the Vertex AI, that account you have to select here. So this is my Google Cloud account. I'll just try to select. Now it is also asking for password. So let me give my password and I'll click on next. So if you're doing for the first time, so it will give you this kinds of authentication. It's just a one-time authentication. Okay, that's it. So guys, as you can see, my runtime is connected. Now, if I execute the cell, if you want to execute the cell, just press Shift and Enter. The same thing, the way actually you execute any Collab notebook, you can execute as the same. Now see, I'm getting the OK output. Now you can also download this notebook. So there is a download button. You can also download the notebook. So first of all, let's do the coding. After that, you can also download this notebook. Even I will also share this notebook with you in the resources section. Fine. All right. Now see, here we'll be using actually Vertex AI. Okay, we'll be using Vertex AI services. That means we'll be using Model Garden. So from the Model Garden itself, what we'll do, we'll try to access different kinds of foundation model. Got it? And if I want to use Model Garden, that means the complete Vertex AI, I have to install one library. So you have to install Vertex AI SDK for Python because we'll be using Python code, right? And if you're using Python code, you have to install this library. So here I want to install the upgraded version of the package. And this is the package name, Google Cloud AI Platform. Got it? If you want to use Vertex AI, you have to install this Python package. Now let me install. Okay, now after installing, it will tell you restart the runtime. Just click here. So it will automatically restart the runtime. After that, you just need to import Vertex AI. Okay, just to test whether everything is fine or not. Now see, if I import, it should work. See, it's working fine. There is no error. Fine. Now see, those who are running this code from the Collab notebook, you just need to do two configuration here. So let me show you. So the first configuration you have to do, this one. That means you have to authenticate with the Google Cloud first of all. So here, let me write the code. So first of all, you have to authenticate with the Google Cloud. Okay, from the Collab notebook. And for this, you have to execute this line of code. So here, everything I'm running from the Vertex AI only. That means I'm using Collab Enterprise from the Vertex AI. I don't need to perform the authentication. But if you're running from the Google Collab, that time you have to do the authentication, guys. Okay. So let me show you one example. Let's say if I want to load any model from the Collab Enterprise, that means if I'm using Vertex AI services, I don't need to authenticate it. I can easily load it. Let me show you. So for this, let's import some of the library first. So here I'm importing some of the library. You can see generation config, generative model. Okay. I'll tell you why I'm importing them and what is the use of it. First of all, let me import all of them. Now let's say I want to load one model. Let's say I want to load this Gemini 1.0 Pro model. So you can see there is a model Gemini 1.0 Pro. Just click here. If I click here, you will see the model ID. You just need to copy the model ID from here. Now, if you just go below, they have already given the source code. Here, you can see this is the model ID. Just try to copy this ID and try to paste it here. Okay, that's it. Now, see, if I execute this code, it will automatically load the model. See, there is no error. But if you executing from the Colab notebook, you will see you will get one error. That means your notebook is not authenticated with the Google Cloud. Okay, so that's why you have to execute this line of code. It will, what it will do, it will authenticate first of all. It will ask for the email address. That means which email address you are using for the Google Cloud account. That email address you have to select first of all. Got it? Then the next actually configuration code you have to run. This one, let me show you. This one. If you are using Colab Enterprise, guys, you don't need to execute. But if you are using Google Colab, you have to execute. Now see, this is the code you have to execute. So here you have to pass the project ID as well as your location. Okay, that means region. Now how you will get the project ID? So here you can see on top you have the project ID. Just try to click here. Now see, I'm inside my first project. So here is the project ID. Just try to copy the project ID and try to mention it here. Okay, in this box actually, you just need to paste it here. Then you have to give the region name. And what is your region name? You can see I'm inside US Central 1. So try to mention US Central 1 here. Okay. Then if you execute, it will automatically initialize with the Vertex AI. That means it will authenticate with the Vertex AI with your configuration. Now it will get to know, okay, now you are the correct user. So once it is authenticated, then you will be able to use all the services from the Vertex AI. That is all the foundation model, all the services you can use. Got it? So these two lines actually you have to execute if you are using Google Colab. See, Colab only. And if you're using Colab Enterprise, no need to execute, guys. Okay, you can run as it is. I hope it is clear now. Okay, so now I think you saw how we can load the model. To load the model, you have to use one function called generative model. You can see I've already imported this generative model from the Vertex AI preview.generative AI models. Now import generative model. Inside that, you just need to give the model ID. Now, if you want to use any other model, simply just try to open, let's say you want to use 1.5 Pro model. So just click here. Okay, so you can see Gemini 1.5 Pro model. Now just try to go below. And here is the model ID. So try to copy the model ID. So this is the model ID. Just try to copy and try to paste it here. So that's how, if you want to use any model from the model guidance, just try to copy the model ID and try to paste it inside this function. It will automatically load that model for you. So now let's test this model. So here I'm going to pass one prompt. So here I've already prepared one prompt. Let me show you. This is the prompt, guys, I have prepared. Okay, see, so here I'm using the model object and I'm calling one function called generate_content. Inside that I'm passing the prompt. Why is sky? So here is the prompt. Why is the sky blue? And stream is equal to true. Why I've given stream is equal to true? Because if I show you, if I let's say open the Gemini or ChatGPT, if you can open anything. Let's say if I give this same prompt here now. So if I let's say pass the same prompt, why is the sky blue? Any kinds of prompt if you give, it will give you stream kinds of output. See, it's not actually one shot output. It will give you stream output. So I think here you saw it will give you stream output. That means after one word, it is coming another word. Okay, that's how it is giving stream output, not in one shot. So that's how we also want to get the output from my response. Okay, that's why I've given this parameter stream is equal to true. That means it will give you stream output. Got it? Now see, if I execute, so here you will get one response object. See, this is the object. Okay. So it would be an object. See, this is a generator object. Now here I can apply any kinds of iterator, that means looping, and I can get the response. Now let me show you. So here you can apply looping. So here I'm applying looping for response in responses, and I just wanted to print the text. Okay, whatever text actually I'm having from the response, I want to print it. Now see, if I execute the for loop right now, you will see the response. See, this is the response actually I got, and this response is actually short response. That's why you didn't saw the streaming output. But if it is generating bigger output, you will see the streaming output would be visible. Got it? Now you can try with different prompt. Let's try with another prompt. So I'll give another prompt here. Let's say I'll give what are the latest developments in the automotive industry. Okay, now if I execute, so it should give me the response. Okay, see, this is the streaming response I'm getting, guys. I think you saw. Okay, this is called actually streaming response. See, the complete response I got. Great. Now see, here I pass the prompt directly, okay, in the generate content function. But if you want to pass as a parameter, you can also do it. For this, I've created another example. So this is the example, guys. Just a minute. Just see that. So here I created a variable called prompt, and inside that I've written the prompt. Let's say this is my complete prompt. Create a numbered list of the 10 items. Each item in the list should be a trend in the tech industry each trend should be a less than 5 words. Okay, try now you can give any kinds of prompt. Now here what I'm doing, I'm calling the model object generate content. Inside that I'm giving the prompt. Okay, whatever prompt actually I've defined, stream is equal to true, then again I'm performing the looping operation. Now see, if I execute, it should give me the output. Okay, now you can also customize the prompt. Let's say here I can give translate in Hindi. See, I'm also getting the Hindi translation as well. Got it? So that's how you can also customize your prompt. It's up to you. Now, I think you remember whenever I was like going through the model garden. So I can also open this model in a Vertex AI Studio. I think I showed you. So let's open this model in the Vertex AI Studio. See, if you open the Vertex AI Studio, right hand side, you can see, you can also set some of the model parameter like temperature, output token. Okay. So these are the thing you can also change. So how we can change with the help of Python code, because as a developer, we have to use with the help of Python code, not from the UI interface. Got it? From the UI interface also, you can use the model, but as a developer, we have to use from the Python SDK. So here we can also set the model configuration. So let me show you. So for this, you have to use this function actually. So I think you remember the generation config. Okay. So let me show you. So I already prepared. So inside generation config, I'm passing all the parameter. Okay. Let me the temperature, top P, top K, candidate. Okay. Max output and so on. And I think you already know these are the parameter I already explained previously. What is temperature? What is top P, top K? Got it? Here temperature means here you are assigning the model creativity, like how much creativity you want from the model. If it is close to 1, that means it will take risk. It will be more creative. If it is close to 0, it won't be taking any kinds of risk. Okay, that's the idea. Now this generation config you have to pass as a parameter of generation config. Here you can see generation config is equal to generation config. And the same prompt I have given, stream is equal to true. Again, I'm looping through the response. Now if I show you, now I'll see that your output would be more creative. Okay. So previously, I think you remember we got actually very short output. Now see, this output is more creative right now because we given the configuration model parameter right now. Okay, I hope it is clear. Now let me show you another thing you can do. This is called actually test chat prompt. Now what is test chat prompts? Let me show you one example. Let's say here I ask one question, why is the sky blue? Okay. Now this prompt actually I have given and my Gemini will try to remember this prompt. Now if I ask, give me the answer in bullet point. Okay. Now see, here I haven't mentioned I want this answer. I just give me the answer in bullet point. It will automatically remember my previous, let's say, context. Okay. That means I want to ask this particular response. Now see, it has given me in the bullet point. Okay. So this is called actually memory. That means it is trying to remember the chat history. So that thing you can also perform here. So let me show you. So for this, you have to use one more line here. This is the line, guys. Model.start chat. So this start chat will automatically remember all the conversation you are doing with your large language model. Now this is the prompt actually I have given. My name is Bappi. You are my personal assistant. My favorite movies are The Lord of Rings and Hobbit. Suggest another movie I might like. So this is the prompt I'm giving, and this is the stream is equal to true I'm giving. And now see, if you're using chat, that time you have to use chat.send message. Okay, chat.send message, because here you have initialized the model. I think you remember. Now see, if I execute the program. So guys, as you can see, I got the output. Okay. Now what I will do, based on this answer, I will ask another question. So because it has remembered my previous context. Huh? So here now asking, are my favorite movies based on a book series? This is what actually I'm asking. Now see, if I ask this question, see, it will refer my previous actually context. Yeah, you can see both the Lord of Rings and the Hobbit trilogies are the based on the book series. Okay, by J.R.R. Tolkien. Okay, now I can show you the story. So if you want to see the story, just write chat.history. So it will show you the entire story. See, so first of all, you ask this prompt, your model has given this answer. Then again, you ask this question, your model has given this answer. Got it? I hope it is clear. Fine. So that's how actually we can use any kinds of language model. Now let's try to see any multi-model. That means we'll be also using some vision model. So I think you know, here actually we are also having some vision model as well. So this is my model garden. Now just click on the vision model. You will see there are different kinds of vision model are available. So from here, I'm going to use one vision model. So Gemini 1 Pro vision model. So you can search this model here. Now, if you want to load this model, you can load like that. This is the model ID. So let me show you this model. I'll copy the name, and in the model garden. So here you can search this model. You will see Gemini 1.0 Pro vision model. Okay. Now see, this is the vision model. So with this model, actually, you can also work with the images and videos. Okay. Now this is the model ID you have to give. Now I've given the model ID. Now let's load the model. Fine. Now here I'll be working with images and videos, and to work with images, videos, I need some helper function. That means this helper function will help me to load the image, visualize the image. Okay. So here I have created some helper function. Let me show you. So these are the helper function I created. You can see different helper function I created. Display image. So it will display the image. If you want to get any image as a bytes from the URL, you can get with the help of this function. Load image from the URL, you can use this function. Get URL from the GCS, you can use this function. Print multi-model prompt. That means if you want to print any multi-model prompt, you can use this function. Okay, so that's how we can create some utility related function, and this function you will get over the internet. If you just simply search how to display image, give me a function, you will get this kinds of code. Okay, so I have initialized, these are the utility related function as of now. Okay, so here the first thing I'm going to show you how to generate actually caption from any image. Okay, so for this, let's see one example. This is the example, guys. So here I'm downloading one image. You can see this is the image URL. So guys, you can see this is the image. Okay, this image actually will be downloading. So here, let me show you. And how we are downloading the image, we're using gsutil command. Okay, so if you execute this command, it will download the image from the URL. Then I'm loading the image. Then I'm giving a prompt, describe this image. Okay, I'm passing the image as well as the prompt. Then I'm using the multi-model. That means the model we have loaded, I think, remember this Gemini 1.0 Pro vision model. Okay, you can also use any other vision model. So simply go to the model garden and try to choose any other vision model. You can use as it is. Okay, now let's get back. Now whatever actually, let's say output I'm getting, I'm just rendering. Okay, that's it. Now let me show you. So guys, as you can see, this is my results I got. So here I've given a prompt and this is the image. Now it has given me the caption. So the image shown a gray cat with black strips walking in the snow. The cat has yellow eyes and long tail. You can see yellow eyes and long tail. Cat is walking towards the camera. Okay, that means this is a great caption my model has given me. Now let me show you another example. So I prepared another example. So guys, you can see I'm using another image. Now if I show you this example, see, this is my prompt. I have given describe the image. That means describe the scene. Now see, this is the response I got. Now this is the response to pontoon boats are anchored in the Charles River in Boston. In the background are two breeze and Boston skyline. So guys, as you can see, this is a correct caption my model has given me. Okay. Now if you want to use load image function, that means the function we created in the utility function to load this image URL, you can use this load image URL function as well. And with the help of that, we can also do the same thing. Okay, there are different techniques you can load the image. You can also use OpenCV to load the image. Okay, it's completely fine. Now see, I'm getting the same output. Now here we'll be learning another thing. Here we'll be combining multiple image and text prompt for the few shot prompting. That means here I'll be passing the few shot to my model, and my model will try to give me the response. So let me show you one example I prepared. So this is the example, guys. So here I'm using 3 images. So let me open all the images. So this is stored in the Google Cloud storage. Okay, you can see this is another image. So you can see this is one of the images, this is another image, and this is another image. So these 3 images actually I'm using here, and with the help of load image from URL, I'm loading both 3 images. Then first of all, I'm giving the prompt for 2 images. You can see these 2 images I'm giving the prompt. This one and this one. This one I'm not giving any kinds of prompt. Okay, you can see I've given city is equal to London, because you can see this is a London city and the landmark is a Big Ben. Okay, it's a Big Ben. So you can search on Google Big Ben, I think. Yeah, see, this is the Big Ben. Okay, so that's why I'm giving some prompting. That means I'm giving the label. Okay, now prompt 2, the second image I'm giving, this is the Paris city. City is equal to Paris, and landmark, you can see it's Eiffel Tower. Okay, you can see it's Eiffel Tower. And the third image, I'm not giving any kinds of prompt. Now let's try to see my model is able to generate the actual, let's say, prompt for that particular image or not. So here you can see I'm passing my image 1, prompt 1, image 2, prompt 2, and I'm only giving the image 3 here, not the prompt. Now I'm using the multi-model and generate content. Now let's try to see whether it is able to identify that image or not. See, these 2 actually I have given, it's fine. Now see, third one, city, Rome, landmark, Colosseum. Okay, so let me copy and let me try to verify. See, correct. It's the correct one. Okay. So beautifully, my model is able to generate the response. So this is called actually few shot prompting. Now also let's try to see some video example. So what I will do, I'll download one video. So this is the URL of the video. I'll download this video. Let me download and let me show you here. So I think you remember Google has launched one phone actually called Pixel. Okay, you can see this is the Pixel. This is the Pixel advertisement. You can see this is the Pixel advertisement. Okay. So this video actually I have downloaded from the URL. Now I will give this video to my multi-model and I will give some prompt. Let me show you. So I already prepared one prompt. This is the prompt. Answer the following questions using the video only. What is the profession of the main person? What are the main features of the phone highlighted? Which city was this recorded in? Provide the answer in a JSON format. Now see, if I give this video and if I pass it to my multi-model, it should give me the response. See guys, I got the response. Now you can see the person name is Sheikha Shimada. Profession is a photographer. Brand is Google. Phone brand is Google. Model is Pixel 8. And you can see the features: video boost, night sight, city Tokyo, country Japan. Amazing. Okay, amazing. Actually, response I got. Now you can use any kinds of video. You can do the caption generation. Got it? So that's how guys you can export different kinds of model in the model garden. It's not like only Google model. You can also, let's say, use Meta model as well. Let's say you want to use Llama model. Just simply click on the Llama and try to open this notebook. So they have already given all the code example and everything. Okay, only just you need to execute and you have to see how we can access the Llama model and all. Got it? So just try to explore guys. This is up to you because all the model I can't show you. So I have just given the demo like how we can access different kinds of foundation model. Now you'll be exporting whatever model actually you need later on. Got it? Okay. And one thing guys, after implementing all the code, what you can do, you can download this notebook. And after that, you can delete this instance. Okay. No need to keep on running. Just try to delete the instance. Otherwise, you can also stop the instance, but I will try to delete it. Okay. I'll just try to do the confirmation. So after some times, actually, you'll see that this notebook would be deleted. Okay. Now see, this is deleted. So yes, this is the actually hands-on part of this Vertex AI. So in the next video, we'll try to see how we can do the setup, everything on our, let's say, local machine. That means how we can connect this Vertex AI with the help of local machine. That means we'll be coding everything in our VS Code. From the VS Code itself, we'll try to access the Vertex AI model. That means foundation model. Okay, so we'll try to access the model garden from the VS Code. So for this, whatever setup actually required, I'll tell you each and everything to see how we can use this Vertex AI from our local machine. That means we'll be doing the setup, everything in our local. So previously I showed you how we can use Collab Enterprise. That means everything I was performing in the G Cloud. But in this video, I'll try to use my VS Code. And to access this Vertex AI, what are the configuration we have to perform? We'll be learning each and everything. Because see, going forward, whenever you will be implementing projects, right, end-to-end projects, so you have to implement through the VS Code, right? And if you want to implement through the VS Code, you have to know how to configure this Vertex AI in your local machine. Okay, so that's why it's super important to know how we can set up everything in our local machine itself. So for this guys, you need one tool actually. So the tool name is GCP CLI. Okay, GCP CLI install. Just search GCP CLI install on the Google. So after searching this GCP CLI install, if you just go below, you'll see this link actually. Install the G Cloud CLI. So just try to open it up. Now here you will get the installer. See, download the installer. So I'll click on the link. So it will automatically start downloading this CLI for me. See, it has downloaded. Okay. And if you're using any other operating system, let's say Linux, then Debian, Red Hat, CentOS, macOS. Okay. All the command is already written here. You can follow the command and you can install this G Cloud CLI in your system. Because see, with the help of this G Cloud CLI, we'll be doing the authentication with our account. Okay, that is the thing. Now I have already downloaded it. Now what you have to do, just double click and try to install. So the way actually you install any kinds of normal software, you have to follow the same step. Okay, there is nothing new. So for me, I already installed. See, after installing, just search for Google. So you'll see this Google Cloud SDK shell. Just try to open it up. So we'll see this kinds of window. Okay, if you are getting this kinds of window, that means you have installed successfully. Okay, now let me close it. Now what I will do guys, I will open up my local folder and here I'm going to open up my terminal. You can open up your any kinds of terminal, whether your Anaconda terminal, Git bash terminal, anything. Now let's also open up my VS Code here. All right, so here the first thing what you have to do, guys, you have to create one virtual environment. After that, you have to install all the required packages. Okay, then after that we'll be writing our actually code, okay, with the help of Vertex AI. So to create the environment, you can execute this command. So conda create -n, let's say Vertex AI demo Python is equal to, let's say I'll take 3.10 -y. Now let's create the environment. Okay, it's done. Now let's clear. Before clearing, I have to activate the environment. So this is the command. Let's try to copy and try to execute it here. Now let's create a file called requirement.txt. So I'll just create this file, requirements.txt. Inside that, I will mention all the requirements I need. So these are the requirements, guys, I need. I think you remember. So I think you remember, to use the Vertex AI, we have to install this package, Google Cloud AI Platform. I think in the Collab Enterprise also we did the same thing. Then Streamlit I want to use because I want to create a simple user interface. There actually you can give a prompt and you can get the response. And python.env because I'm going to manage my GCP credential. Okay, that's why. Now here, let me create this file as well. So .env. Okay, inside .env, you need actually your project ID. Okay, then you need region. I'll tell you how to collect this project ID and region, but before that, let's do the configuration, okay, with our G-Cloud. So first of all, let's me install all the requirements. So I'll just write pip install -r requirement.txt. All right, so installation is completed. Now let's do the configuration with our G-Cloud. So for this, you have to execute this command called G-Cloud init. Okay, just try to execute this command, guys. So if I execute this command, you will see that. See, if you're doing it for the first time, you will get this kinds of window. You must log in to continue. Would you like to log in? I'll give yes. So guys, now here you have to select the account. The account actually you are using for your G-Cloud account. So this is my account. I'll select. Now you have to provide the password. So this is my password and I'll try to do the next operation. Okay, and then click on the continue and allow. Okay, now you can see I'm done with the authentication. Now if I come back, see, now actually I'm getting my project ID. You can see I'm getting my project ID. Got it? So let me show you. If I go to my dashboard, now if I click here, this is my project ID. Studios loader 4361. I think you can see that. Studio loader 4361 and 2. Okay, so this is my project ID. Yeah. Now, if you already have one existing project, you can select it. Either you can create a new project. So for me, I already have the projects. I'll just select the one. I'll select the one. That means my existing project. Now it is asking for, do you want to configure a default compute region and zone? I'll give yes. Now it is telling which region you actually want to take. So what I will do, I'll take this region actually. So central US. So let's say I will take this one, US central 1C. So I'll give 7 here. Okay, now I think it is done. Now let me clear my terminal. Okay, so everything is set. Now let's create one file here called main.py. Inside that, I'm going to write all of the code. Okay, that means we'll be trying to access one. That means here we'll be trying to access one model from the model garden. But before that, you have to set this env. So you have to give the project ID. So here is the project ID, guys. I think I showed you how to get the project ID. This is the project ID. Just try to copy. And here, try to mention it. Then you have to give the region. So I think region I already showed you. So here you can check the region. Click on the Collab Enterprise. Left hand side, you can see US-Central 1. Just try to select it. US-Central 1. Okay. Now just try to verify it. US-Central 1. Okay. So it's fine. Now let me save. Now let's create the main.py. So first of all, let's import all the necessary library. Yeah, so these are the library I need, guys. I think you remember I was also importing them in my Collab Enterprise. So Vertex AI, then Streamlit I need for the user interface. Then I'm also importing some of the necessary, let's say, function from the Vertex AI preview generative models. Okay, so I need generation config and generative model, and .env I need because I want to load this env file. Now let's select my current environment. So this is my environment. Okay, now this arrow will be disappear. Now the first thing, I'll load my project ID as well as the region from my environment. Okay, for this code snippet you have to run. Got it? Then I'll be initializing. Then I'll be authenticating with my Vertex AI. So this is the authentication code, guys. Vertex AI.init. You have to give the project ID as well as the project location. That's it. Now let's load the model. So here I'm going to load one model from the model garden called Gemini 1.0 Pro. So let me show you. If I go to the model garden, so this is the model, guys, I'm trying to load. Just click here and you will see the model ID. So just try to copy the model ID and you can use it. So this is the model ID, guys, here. Just try to copy and mention it here. Okay, that's it. Then I've created a simple function. Let me show you. So this is the function I created. Inside that, what I'm doing, I'm just first of all creating my Streamlit title. First of all, I'm setting my page configuration like Vertex AI demo. So it will give you one name. Then I'm setting the header. That means what will happen? It will give you one title. So here you can give any name. So here I've given, let's say, Gemini on Vertex AI, or you can give Vertex AI local demo, because everything we're doing in the local machine. Okay. Then user will give one question. So that's why I've taken a text input box, and this question actually I'm passing to my model. You can see. Okay, if there is a question, it will execute this model. Otherwise, it won't be executing. Okay. After that, actually, I'm going through the response and I'm printing in my console. Okay. That means in my Streamlit console. That's it. Now, if I want to execute, I have to call the function as well. So let's call the function. That's it. Now let's try to execute and try to see whether it's working or not. So I'll write Streamlit run app.py. Sorry, main.py. I think it's. Now let's give the allow permission. So this is the interface, guys. Now here you can ask anything. Let's say I'll give hello. Let's see. You can also see the terminal to get the log. Okay, you can see it is giving me one error. It is telling Google authentication default credential. Your default credential are not found. To set the default configuration, you can visit this link. So let's open this link. And I think it will suggest me some command there. So let's copy this command. And now I'll execute from my terminal. I'll stop it. Now let's execute. I'll select my account. The account actually I'm using for my G-Cloud. So I'll give my password. Next. So if you're doing for the first time, so you might get this kinds of issue. So once this setup is done, you can use it as it is. Okay, now I think it is done. Now let's execute the application again. Now let's give hello. Okay, guys, now see, I got the output. There is no issue. That means what you have to do, you have to set the credential as a default actually, okay, credential. So that's why we actually executed this command, G-Cloud auth application default login. Got it? Now see, I'm getting the output. Now here you can pass any kinds of prompt. So here I can give, let's say, tell me about Python. Okay, see, I'm getting the entire response. Okay, got it. So you can now ask any kinds of question. That means from our local machine itself, now we are able to access the model garden. That means by Vertex AI services. All right. Okay, great. So yes, guys, this is all about from this video. Now we'll be using this technique going forward whenever we'll be implementing any kinds of project. Okay. So in the next video, we'll try to see how we can implement a RAG-based application. Okay, with the help of actually Vertex AI platform. And we'll be using some Vertex AI services there. All right. So as of now, we saw how we can use model garden. That means how we can access different kinds of model. On top of that, how we can perform the inference. But let's say if you have some custom data, and with the help of that custom data, you want to create a knowledge base and you want to connect your large language model there. Okay, and you want to perform the query operation on top of it. So how we can perform it. And this is called actually RAG. I think I already explained, okay, in my previous video. So if you're not sure about the RAG, guys, first of all, check those videos. Then you will be able to understand, okay, what I'm trying to implement here. So that means, let's say here I'll be using my custom data, and with that custom data, what I will do, I will create a knowledge base. Okay. and I'll just try to connect my large language model there. Then I'll be performing the query operation on top of my data, the data actually I have uploaded. This is the thing we'll be implementing. And here technology wise actually we'll be using the Vertex AI, entire Vertex AI platform. That means here everything will be using Google Cloud services. Okay, we are not going to use any third-party services. That means to store our data we'll be using Google Cloud Bucket, and to store our embedding we'll be using vector store. Okay, vector store service from the Vertex AI. This is one of the vector database they have created. Okay, this is called actually vector store. So we'll be using all the Google Cloud service only, not any other service. Okay, in this video. So for these guys, you can see I prepared one notebook in the Collab Enterprise. So first of all, try to connect the notebook. After that, you can check with the help of OK command. And if it is giving the OK message, that means notebook is running. Then the first thing what you have to do, we have to install. These are the library. As I have told you, we'll be using some custom data. I'm going to use PDF document. That's why I'm installing this PyPDF2. Okay, this library. Then Google Cloud AI platform, because if I want to use the Vertex AI, I need to install this package. Then I already told you we'll be using custom data. That means custom document. And to store this custom document, I'll be using Google Cloud Bucket. I think you know Google Cloud also provides bucket service. Let me show you. So if you just open Google Cloud and search for bucket, so this is the bucket. So here you can create different bucket, and inside a bucket you can store the data. See, I already created one bucket called Start Content 2024. Inside that I'm having one documents. I'll tell you how to upload this document here. As of now, just try to consider we'll be using this bucket services to store my content. Okay, and no need to create manually, it will automatically create. I've already written the code for it. So these are the packages you have to install. For me, I already installed everything, so I'm not going to install again. Now see, you have to import. These are the library right now. So here I'm importing storage from google.cloud, because I told you we'll be using bucket, and to install bucket I need this actually function. Then I'm also importing text embedding model from the Vertex AI language model, because here we have to perform the embedding generation, and to generate the embedding I need some embedding model, and here I'm going to use Google embedding model. Okay, from the Vertex AI, from the model garden. That's why I have imported this text embedding model function. Then I also imported AI platform PyPDF, and these are the library I also imported here. And here I'm using UIID. Okay, why I'm using UIID? Let me tell you. See, there is a reason actually I'm using UIID. See, if you're using Vertex AI, this RAG would be slightly different. Okay, slightly different. That means, let's say whatever documents you will be publishing. Let's say I will be publishing one statistics PDF I'm having. Let me show you the statistics PDF. So guys, as you can see, this is the statistics PDF actually I'm having. So this particular data actually I'll be using as my custom data. Now what will happen? First of all, I have to extract the documents from the PDF, yes or no. So after extracting, what I will get different documents. I think you know, I'll get different documents. That means doc1, okay, then doc2, and so on. Now what will happen? This document I have to convert to embeddings as well. That means it would be converted to embeddings. So let's say you will get some vector here. Let's say 0.29, 0.55, 0.88, and so on. Let's say this is the vector representation of this doc1 and doc2, and so on. Let's say I'll just get some dummy vector here. Now here what I want to do, with the help of this UIID, I want to assign some unique ID. Let's say the document one it has extracted, I will assign one unique ID. Let's say this is the unique ID. Let's say 1210. Let's say this is the unique ID. Okay, it has assigned to the doc1. Then in the doc2 it will assign another unique ID. Let's say 1211. Okay. Now what will happen? This unique ID also would be assigned in the vector, because this vector is representing this documentation. Yes or no? Okay. That's why this ID would be there, 1210. Then this ID would be also there, because this vector is representing this document. So 1211. Now what will happen? Let's say whenever you will perform the similarity search operation, that time what happens actually, it will return the relevant answer, yes or no. I think you know, whenever you implement any kinds of RAG, whenever you perform similarity operation, it will give you some relevant answer. Okay, relevant answer you will get. Okay, and from where you will get the relevant answer? From the documents only you will get the relevant answer, the documents you are having. Okay, now let's say it will give you this relevant answer. Let's say doc1. Whenever it will give you doc1 relevant answer, that means it will return the vector, because your model will only return the numbers, not the text. Okay, and this particular number will map where? In this document. That means this document is representing this vector. That means whenever your model is generating this vector, that means it will map these documents. That means the text. Okay, how? With the help of this UIID. Okay, with the help of this UIID. So it will look for where this UIID is present. That documents actually it will show you as a relevant answer. Okay, now I think it is clear why I'm using this UIID to give to assign actually unique ID in front of my documents and in front of my vector embeddings. Okay, now I think it is clear. Now let me clear my board. Now the next thing what you have to do, guys, you have to initialize some of the variable. Now see, if you are doing this project from the Google Colab, first of all, you have to authenticate with your G Cloud. And how to authenticate, I already shared you two code, I think you remember, two configuration code I shared with you in my Vertex AI demo session. So you can refer the notebook and you can first of all authenticate with your Google Cloud. Okay. And I said until you are not doing the authentication, it won't be working. I'm running from my Colab enterprise. That's why I don't need to do the authentication. So if you're running from the Colab, Google Colab, so you have to activate this line actually, project. So you have to give the project ID here. How to collect the project ID? This is the project ID. Got it? So here I'm running from the Colab enterprise. So I don't need this variable. I'll just try to comment it out. So here what I need the location. And this is my location. Then PDF path. So where you have to upload the PDF. So in the files, actually you have to upload the PDF. Let me show you. So here you can right click and upload and try to select the PDF. Whatever PDF you are having, just try to open it here. It will automatically upload here. See, for me, I've already uploaded. And these two files would be generated as of now. See, I already executed this project. Okay, that's why all the artifacts you can see. Okay, but for you, it would be empty initially. So this two file would be created. How it will be created, I'll tell you. As of now, just try to consider we have uploaded the statistics.pdf file. Got it? Then you have to give the bucket name. So you can give any kinds of bucket name and make sure this bucket name should be unique. So this bucket would be created automatically in the bucket section. See, it is already created for me. Again, this would be created automatically. You don't need to create it manually. Then here you have to give embed file path. What is embed file path? Because see, I already told you, first of all, we have to extract the documents from my PDF. Then what we have to do, we have to generate the embedding as well with respect to the documents. And these documents and this embedding, I'm going to save in a JSON file. Okay, that's why I'm just creating some JSON file. You can see these two JSON file I'm creating. Okay, starts embedding .json and starts sentence.json. Inside sentence.json, it will store all the documents, that is the English text, and inside embedding, it will store all the your embedding. Okay, embedding of the sentence. That means whatever, let's say, documents you are having. That means whatever documents you have, okay, with respect to that, it will store the embeddings as well. Okay, with the unique ID. So that is the thing. Then you have to give the index name. Index name means, let's say here we'll be using vector search, and inside vector search, we just create an index. The way actually we used to create the Pinecone index, I think remember, we create an index here. So this is the index name. It will automatically create that index. Now here I've written a function. This function will extract the sentence from the PDF. So it will take the PDF path and it will give you the sentences. That means all the documents it will give you. Then I have written some of the helper function, guys. You can see generate text embedding. That means this function will generate the text embedding. It will take the sentence and it will generate a text embedding with the help of text embedding model. You can see I'm using text embedding gecko model. So this is the model, guys, text embedding gecko 001. So this model is available in the model garden in Vertex AI. Got it? Then I have written another function, generate and save embedding. That means this function will actually add the unique ID in front of your sentence. That means documents, and in front of your embeddings. That means vector embeddings. Okay. That means it will generate this both file. Okay, and it will save as a JSON file. You can see here I'm doing it. I'm first of all actually creating my embedding. Okay, and I'm adding the unique ID. I'm also creating the sentence. I'm adding the unique ID. Then I'm saving in a JSON file. Okay, this is the thing actually we are doing. That means this function is responsible for creating these two files, and it will store your sentences, and it will store your documents as well as the embedding with the unique ID. Okay, that's it. Then there is another function I created called upload file. That means after let's say generating this file, I have to upload this start sentence.json in the bucket. And how I will push to the bucket, we will be using this function upload file. You can see if you go to the bucket section, so this file is already present. Okay, so if you want to push any kinds of file, you can use this function. That means we created some helper function. This helper function will help me to do certain operation. This is the thing. Now here another function I have written called create vector index. So this function will create the vector index in the vector source. Okay, in the vector source vector database, and each of the dimension would be 784. I think you remember previously we used sentence transformer actually embedding model, and we used to create I think 384 vector representation. I think you remember, right? But if you are using this text gecko model from the model garden, your vector dimension would be 768. This is the dimension, and you can see with the help of AI platform actually library, we are creating the index. So this function will automatically create the index for you. Got it? Then after that, I'm calling these are the function. You can see first of all I'm calling generate and save the vector. I'm giving my PDF path. sentence file path as well as the embedding file path. Then I'm also uploading this file to my bucket. That means if I execute this line, what will happen? It will create this two file first of all. Let me open it. So this is my sentence. That means this is my document. And you can see, first of all, it will show you the unique ID. Then it will show you the sentence. Okay, that means this is the document it has extracted from the PDF. With respect to that, it has also saved the embeddings as well. Let me show you. So this is the embedding, and here you'll see the unique ID. That means the same ID, and now this is the embedding representation. Okay, I hope now it is clear. Now, so once it is executed, then upload file will execute, and it will upload this sentence.json to my bucket. Now, if I show you, see, bucket would be created, and inside bucket actually, you will see this start sentence.json would be present. Okay, because later on, whenever I'll perform the, let's say, similarity search operation, I need that file. I need to download that file. With that, I will do the search operation. Okay, similarity search operation. That is the thing. Now, the next thing, what we'll be doing, we'll be creating the vector index. That means we'll be creating the index, and inside index actually will be storing all of my vector. Okay, so here you can see I'm giving the bucket name. That means from the bucket name, it will load this file. Okay, it will load this file. That means the sentence file. So sentence file it will load. Then it will also take the index name. And with the help of actually that embedding model, it will generate the embeddings of that documents. The documents actually we are having, and it will store to the vector database. That means inside my vector source. Now, if I execute this line, okay, if I execute this line, it will take some time. It will, that means it will process all the data. It will store to the vector embedding. After that, if you open it up, let me show you. So if you open it up, so you'll see that it will create an index. The name actually you have given start index. Okay. Now you can see both places you are getting this green tick icon. That means everything is executed successfully. If you are getting any red icon, it's not completed. Okay. That means there are some issue. Now, if I click on the deployed index, you'll see one ID here. So we need this ID later on. So guys, you can see this is the ID. The last number you can see, this is the ID. So we need this ID later on. Okay, see, this is the ID. This ID actually we need later on. So now let's get back to my collab. Now again, just import some of the necessary library. Then again, set these are the actually variable like your location, sentence file path, and index name. That means the same index name. Okay, same index name you have to give. Start index. Okay, that's it. Then just load the model, large language model here. So here I'm using Gemini Pro. You can also load any other model. Then just try to load the index. That means index endpoint you have to load. And to load the index endpoint, you just need to give this ID. And how you'll get the ID, guys, I already told you. So this is the ID. Just try to copy this ID and just try to paste it here. Now if you execute, it will load the index ID. Got it? That means this is going to be your knowledge base right now. And this is going to be your model. Now again, I have written some of the helper function generate text embedding. That means whatever user will give the prompt. Now let's say I have given one prompt. This prompt should be also converted to the embedding. Okay, then this function will help me to do that. Then I've written another function generate context and load file. That means it will load that documents file and it will generate the context. Okay, that means if you are performing similarity search operation, it will give you some rank results, and how it will give the rank results with the help of these two function, it will give the rank results. Now here I've loaded the file. Then you can see. Then this is my query. Let's say what is correlation. First of all, I'm generating the query embedding with the help of that embedding model. And if you want to see the query embedding, see this is the vector representation, guys. This is the entire query embedding. Now let me comment it. Now this query embedding I will pass to my vector source. Okay, now you can see find neighbor. It will give me 10 rank results. Okay, 10 rank results actually it will give me. Then this response actually I'm giving to my model. Okay, this is the code snippet. My model will try to analyze this response, even the query I have given. Based on that, it will give me one response. Now if I execute, see, if I execute this last line of code, see, here you will get the response. Correlation is a statistical measure that indicates, see, blah, blah, I'm getting the output. And here you can also give the prompt based on the context delimited in the brackets, answer the query. Okay, that's how you can give any kinds of prompt. And that's how actually we can build retrieval augmented generation kinds of application, okay, with the help of Vertex AI platform. And all these steps, guys, I have mentioned here. So if you are implementing any kinds of RAG based actually application, you can follow the same step. Okay, even you can also perform in your local machine. That means I told you how we can connect our local machine. That means how we can connect our VS Code. So with the help of VS Code also, you can create this kinds of RAG application, and you can create a user interface. Let's say you want to create a Flask interface, you want to create a Streamlit interface, you can also create. So this task actually I want to assign you. Just try to create one user interface. So you have to use the same logic, only you just need to integrate one user interface. That is the idea. Okay, I hope it is clear. Now see, once it is done, now if you want to terminate all the instance, what you can do. So first of all, just try to delete this. So first of all, just try to delete the bucket. To delete the bucket, just try to select the bucket, and there is a delete button you will see. Just try to click on delete, and delete confirmation you have to give. So it will delete the bucket. Then you also need to delete the index. So to delete the index, just go to the index, vector search. So first of all, you have to do the arn deploy. Then you can delete it right now, I think. Now there is a delete button. Just try to click on delete. So it would be deleted. Okay. So that's how you can remove all the instance you will be creating. Okay. So I think guys, this is helpful. I showed you the entire like process how we can implement RAG. Okay. See, I think you already saw how we can set up everything in our local machine. That means if I want to connect with my Vertex AI, so what are the setup actually I can perform? So setup wise, I already covered in my previous video, so you can check it out. So here actually I've already prepared everything because see, most of the code are similar, whatever things we implemented previously. So make sure first of all you configure everything, your account, then your let's say configuration, everything you just prepared. After that, in the env file, just try to change this project ID and region. So let me copy my project ID. So just try to click here. So this is my project ID, guys. Just try to copy and let's mention it here. Okay. And region, I'm inside US Central 1 only. I don't need to change it. Now the next thing, you have to create an environment. How to create the environment, I already told you. Okay, I'm using the same environment, Vertex AI demo. Now you have to install the requirement. So one more requirement I've added called Flask. So let me install the Flask because in this project, I'm going to use Flask. Okay, Flask framework to create the front-end application. So for this, just write this command, pip install -add requirement.txt. Now it should install the requirements. So guys, many people were asking me how to install actually GPU, NVIDIA GPU in our local system. For this, what I did actually, I created one video in my YouTube channel. Let me show you. So if you go to my YouTube channel, guys, this is my YouTube channel. You can also subscribe me here. Now, if I go to the video section, so here I already created one video. Here you can see the video, set up NVIDIA GPU. Okay, so here I showed you all these steps you can follow to set up your NVIDIA GPU for the deep learning task. Got it? So let's say if you're having good GPU and if you want to, let's say, execute open source large language model in your local machine instead of using Colab, you can refer this video that time. And make sure, guys, you subscribe to this channel because here also I create lots of content related generative AI, MLOps, then end-to-end project implementation, okay, computer vision, everything. Now let's get back. So I think installation is completed. Yeah. Now see what I have done. I created one template file and inside that, this is my HTML code because you already know if I want to use Flask, I need a HTML, okay, HTML code to create my front end part. And again, I used the Bootstrap website to prepare this front end. I'll tell you whenever I'll execute how it will look like. Now, this is my endpoint app.py and here I've imported all the necessary library. And these code are common. I think you know we are doing the authentication with my Vertex AI. Now, this is the route I created. This route is my default route. It will launch my index.html page and this is my prediction route. That means whenever user will give any query, okay, user input, I'm getting the user input and this input actually I'm passing to my model and whatever response actually I'm getting, I'm showing in my Flask server. That's it. Now let me execute the application. So what I will do, I'll run this application in the port number 8080. Save it. Now I'll open up my terminal and let's execute Python app.py. Okay, so it is running. Now let's get back. Localhost. Now see, this is how your user interface will look like. Now you can give any command. Now here you can give any query. So I'll ask what is Python. Now send a request. You can also see the log in the terminal. See, I got the response. So this is the complete response I got, guys. Got it? This is the complete response I got. Now if you want to ask another query, just try to refresh. Again, you can pass that query. Okay. Now that's how actually what you can do. The previous RAG application we implemented with the help of Vertex AI, you can create your custom RAG. That means you can use your custom documents like we did one project like, I think you remember, medical chatbot. So that's how you can use your custom documents and you can create this kinds of application. And this is the front end you can use as it is. Got it? All the HTML code I will share with you. So yes, guys, that's how we can also create LLM powered application with the help of Vertex AI. So as I already told you, in the model garden, you are having so many foundation model. And if you want to fine tune, these are the model. So what are the steps you have to follow? In this video, I'll tell you each and everything. So I think remember previously, whenever we used to do the fine tuning operation, first of all, we had to download that model in our system. Then I was preparing the data. Then I was fine tuning. These are the model. But here, if you're using these kinds of LLM ops platform, you don't need to download these are the model in your system. So here what you have to do, you have to use that model endpoint. That means you will be accessing this model through the API, right? That means first of all, you have to authenticate with the Vertex AI. I think I already told you how to authenticate with the Vertex AI. After that, just give the model ID, which model you want to use. It will automatically hit that model. So here, the only thing you have to do, you have to prepare your data. After that, all the thing would be happening in their server only. Okay. Now let me tell you the step actually you can follow to perform the fine tuning operation. So for this, what I will do, guys, I will use the Colab notebook. So I'll open up Colab notebook. You can also use Colab Enterprise. You can also do it from your local machine. It's completely fine. But as of now, we have explored like VS Code. We have also explored like Colab Enterprise. Now let's try to see how we can also use the Colab. Okay, like our Google Colab. So here, let me change my account. So let's say I'm going to use this account. Okay, this account actually I'm going to use. And make sure the account actually you are using for the G Cloud, the same account you have to use in the Google Colab as well. Okay, otherwise you might get some authentication issue. Now what I will do, guys, I'll just create a new notebook here. So let me create a new notebook. Now simply just connect this notebook. And in between, let me show you the fine tuning step you have to follow. So see, you can follow this blog actually. So this is from actually Google. So Google developer. So they have already given all these steps actually you have to follow to perform the fine tuning operation. So I already prepared all these steps you have to follow to perform the fine tuning. Only I will show you one thing from this blog actually, the data format. Okay, so here let me show you the preparation and loading the data. See, if you are fine tuning on the Vertex AI, you have to prepare your data in the JSON-L format. Okay, see this is the JSON-L format data you can see. So here they have already given one example. Let me open up. So you can see this is the train JSON-L format data, and it is present inside this GitHub. So what you can do from this GitHub actually, see this is the data. You can download this data. Okay, in your system you can download this data. So I've already downloaded. Let me show you. So this is the data. I'll open it with the Notepad++. Now if you open the data, guys, you will see it's a JSON. Okay, JSON structure. That means you will have one key here called input text, and this is the input text, and this is the BBC data, guys. Okay, BBC news data. So in the input text actually they are having the entire news, and they're having another actually key here. Let me show you, or I can perform the Control F operation. Now here I will just write output underscore text. Now if I find it, now see guys, this is the output text. Okay, so inside output text actually what they are having the summary. Okay, summary of that news. So this is the data actually. That's how actually you have to also prepare your data. If you're having any custom data, what you can do, you can prepare your data with respect to that. That means what I'm trying to say, that means in the JSON file actually the first key will have the input. Okay, input underscore text. Okay, inside input text what you will have the entire story. Okay, entire story, and you will have another actually key called output text. Sorry, output text. Okay, so inside output text you will have the summary. Okay, summary of the entire story. So this is going to be your data format. Okay, that's how actually you can take as much as record you can. Got it? I hope now it is clear, the format. So whatever data actually we are having, try to convert in a JSON-L format. And how to convert in a JSON-L format? There are so many converters you will see inside Python. Simply you can execute those converters. It will automatically convert your data in a JSON-L format. Got it? That is the idea. Now you can ask me, sir, where I will get these kinds of data? I think I already told you now. So you can use Hugging Face Hub actually. So there actually will have like so many kinds of data set. So you can use any kinds of data from the Hugging Face Hub. You can download it and you can convert to the JSON-L format. And if you are using your custom data that time, you have to convert everything in a JSON-L format. Okay, this is the idea. Okay, you can see the image also. They have already given the data format. So first of all, you have to take the input text. This is the entire BBC news you can see, and this is the output text. That means this is the summary of that story. Okay, this should be your data format. Now apart from that, they have already given all the steps you can follow. So I've already prepared one notebook. Let me show you what are the thing you have to do. Now let me also add this link in the notebook so that you will have the reference later on. So this is the link I have added. Now here, the first thing you have to install some of the library. So here I'm going to install Google Cloud AI Platform because I want to access the Vertex AI, then datasets, then Google Cloud Pipeline components. Okay, these are the library I have to install one by one. Let me install. So after installing these are the library, you have to restart the kernel. And if you want to restart the kernel, you can use this code snippet actually. See, you can also do it from the UI. Just click on the runtime, restart the runtime. So there is a restart runtime option. Okay, restart the session. Otherwise, you can also execute this line of code. It will also restart your runtime. Okay, now what you have to do, you have to authenticate with your G-Cloud account. For this, you can execute this line of code. So here I'm using actually Google Authenticator. With the help of Google Authenticator, actually I will authenticate with my account. Got it? So now let me execute. So it will look for your account. So it will give you one pop-up screen. Let's give the allow permission. Select your account. Let's say I want to use this account because this is my Google account. Now I'll try to select it. Now you have to provide the password. So guys, as you can see, my authentication is completed. There is no error. That means you are successfully authenticated with your this one, your G-Cloud account. Fine. All right. Now the next thing, you have to select the project. So to select the project, you have to execute this line of code. So let me select the project. So I think you know how to select the project. Click here, copy the project ID, and just try to mention it here. And with this, actually, we'll be initializing our Vertex AI. So let me initialize my Vertex AI. Then let's say set some actually variable. That means my region and the project ID. Again, I'll give the same project ID. Now I have to set one configuration here. For this, you have to execute this line of code. Okay, you have to execute this command: gcloud config set project. This is the project ID. Okay, the project ID actually I'm having here. Now let me set. Fine. Now let's import some necessary library. So guys, you can see I'm importing some necessary library. Now you can ask me from where actually I got this code. If you go to that blog actually, so they are suggesting install and import. See, they're also importing. These are the library. Okay, so just try to read this blog. Actually, we'll see all the steps actually they have written. I'm following the same thing only. Now let me import all of the library. Okay, so I have imported all the library. Now the next thing, I will load my data. So let's upload my data. Either you can upload in the G-Cloud bucket. So from the bucket also you can download the data. If you're having, let's say, huge data, that time you can keep in the bucket. I think I told you. So it is already having one bucket service as well. So you can also open up the bucket. Inside that you can store any kinds of data, and you can also load it here. Okay, so if I show you the bucket, so this is the bucket, guys. So here my data size is not used. So what I will do, I'll directly upload here. So I'll just upload. This is the data. Now with the help of pandas, actually, I'm going to load my data. So now we can copy the path and you can paste it here. Now let's execute. Okay, see, this is the data I have loaded. Now you can see this is the input text and this is the output text. Now if you want to see the shape of the data, you can also see this is the shape of the data. And now we can start the training, and it's like very easy. See, only you just need to execute this line of code. Your training would be started in their server only. Okay, not in my Google Colab actually. It will use their instance. Got it? Now see, here is my fine-tuned model name. So this model name actually I'm giving BBC fine-tuned model. You can give any name. So after fine-tuning, what would be your model name? Okay, that is what you have to give here. Then you can give the pre-trained model. That means which model you want to fine-tune. Here I want to fine-tune text based on 002 model. And if you go to the model garden, you will see this particular model. And if you want to use any other model, you can also give the model ID here. Got it? That's the thing. Now you have to pass the data, that is by DF. The DF actually I got. And you have to set the number of epoch. Training epoch you want to, let's say, train. So here I mentioned 100 epoch. Okay, I want to train as of now. And you have to give the tuning job location. Okay, so I have given Europe West 4. You can keep the default size. If you go to the blog, you will see that they are also using this particular location. Now see, if I execute the program, it will give me one URL. And if I click on the URL, I can see the pipeline. That means completely. That means I can see the complete pipeline. My training process is running. And it will take, guys, like 1 to 2 hours to complete the training. But I can't wait 1 to 2 hours. What I will do, I'll stop the execution. So guys, I stop the execution because it will take time. See, I'm telling you after actually executing this line of code, what you have to do. So you can see one URL. Just try to open up the URL. So this is the URL, guys, and try to make sure you have selected your account. Okay, that GCP account. Then you can see this pipeline. Okay, this pipeline would be running, and this is the jobs. So here you will see all the, let's say, logs. So in the pipeline section, you will see all the logs. That means whether your training is running or not. Okay, and how much time actually it will take to complete. So everything, all the log actually you can see here. Got it? So once this execution is completed, you will see it will automatically stop. After that, your model would be ready. Okay, and then you can use this model. And if you want to delete this pipeline, so what you have to do, guys? So there is a delete button. Just try to click on the delete. and try to delete the pipeline. Okay, it will automatically delete the instance. Okay, and guys, one thing, after completing the training, if you open up your bucket, you will see 2 bucket would be automatically created. Okay, and inside this bucket actually it will save all the model checkpoints. Okay, let's say whatever training it is doing, all the artifacts would be saved inside this bucket itself. Okay, you can see. But once you complete the execution, see, it will already save the tuned model. Okay, inside that you can see the text based on model. Got it? So that's how actually it will save all the artifacts in the bucket, and from this bucket itself we have to deploy our model as an endpoint. Okay, and this model would be available in your model garden. So if you click on the model garden, so there you will see one option. So here is the option, my view my endpoint and model. If you click here, you will see that model would be present here. Okay, I hope it is clear. Now let me show you the next step you have to perform. So previously I already did this actually fine tuning. So let me show you what you have to do after that. See, after that actually what you can do, you can use your trained model. That means the model actually you have trained, and you can do the inference operation. So here I'm giving this prompt actually summarize this text to generate a title. So this is the entire actually prompt I'm giving, and this is the output actually I'm getting. Got it? Now you have to deploy your model as an endpoint. For this you have to execute this line of code. Okay, so this will like deploy your model as an endpoint, okay, to the GCP server. That means this model would be available in your model garden right now. So if I go to the model garden, so here you will see one option, view my endpoint and model. Just click here. In this section actually we'll see your model would be published. Okay, from here actually it will load the model. But what I did actually, I deleted the model because again I'm using cloud platform, I don't want to keep anything. Okay, otherwise it will charge me. So that's why I already deleted. Okay, then after that I was loading that model and I was again performing the prediction. You can see this is the result actually I'm getting from my model. Then I was also loading the base model, that means the actual model, and I given the same actually prompt, and I was just checking the actually output. Okay, whether this output and this output actually good or not. That means which model is giving the better output. And here you can see both model giving the good response. Okay, it's not a bad, although I only trained 100 epoch, but you can see this response is pretty good. Got it? So that's how actually you can perform the fine tuning operation. After that you can deploy your model as an endpoint to the G Cloud. Okay, now I think it is clear. Now you can pick up any other model and you can perform the same fine tuning operation. All right, so these resources would be shared guys in your resources section. From there you can download this notebook and you can perform the fine tuning operation. So guys, as of now we have seen the Vertex AI demo, the complete let's say Vertex AI demo we have seen. We have implemented different kinds of application with the help of Vertex AI. So now it's time to explore another LLM ops platform called AWS Bedrock. So this service is available in the AWS cloud. So make sure you have the AWS account. So if you don't have the account, just try to create one account. Initially, it will give you $300 free credit, but you have to add your card there. Got it? So after login with your console, so you will get this kinds of window, okay, in the AWS. So this is my console. So now here, what you have to do, you have to search for Bedrock. So let me search. So see, Amazon Bedrock. And this is the service actually the easiest way to build and scale generative AI application with the foundation model. So let me open up the Bedrock. Now I'll just click on get started. See, if you're opening for the first time this Bedrock, what you have to do, you have to request for the model access. So there is a button you will see, request model access. Just try to click here and see, for me, I already requested the model. Okay, for me, I already requested the model and I got the access. You can see some of the model actually they didn't given me the access. For this, what I have to do, I have to again, let's say resubmit the access request. Then I think I might get. But for you, what you will do, you will select all the model and try to send the request. Okay, send the request. You will see that in 5 to 10 minutes, actually, they will provide the access. Got it? And make sure you check your region actually, in which region actually you are sending the request. Okay, because that in that region actually your model will be available. So I'm currently inside AP South 1, that means Asia Pacific Mumbai. Okay, so now if I go to any other region, let me show you. So if I let's say go to North Virginia, so there you will be able to see I don't have any access of any model. Now see, it will show you this kinds of window, enable all model. Okay, now if I click here, now just select all the model and try to click on the next. Okay, now you have to submit the request. Okay, you have to submit the request. So let's submit the request. Sometimes actually they will ask for some information. So you also need to let's say submit some information. Let's say your name, email address. Okay, then you can send the request. After sending the request, in 5 to 10 minutes, you will see that they will give you the model access. So guys, you can see after sending the request, actually I got the access. You can see granted access. And some of the model you can see it is still in progress. So I think it will take some time to give me the access. Okay. So that's how actually you can apply for the access. So once you got the access, that means congratulations. Now you can start with the Bedrock services. That means now you got all the, let's say, access of the foundation model. Now let me get back to my, that region actually, Mumbai region. Now see, this is your Bedrock interface. If I click on the overview, now you are having different foundation model here. And what is foundation model? I already told you these are large language model, and different companies also has collaborated with the AWS. Even they have also published their model. Like you can see Amazon is having their own model. Apart from that, Cloudy has like updated their model. Then Cohere, Llama, Mistral. Okay, so you can see all the provider. Okay, all the provider, they have collaborated with the AWS and they hosted their model on the AWS. That means AWS Bedrock. Okay. Now what you can do, you can access this the model through API. Got it? So you don't need to download these are the model in your system. That is the main advantage here. Now you can also play with the playground. Let's say if I click on the chat, so here is the chat, guys. So you can select the model. Let's say I want to select this model. Let's say I'll select this Llama 3 8 billion instruct model. Now if I send any request, let's say hello. So this is my prompt. Now see, it is giving me the answer. So that's how actually it is having different kinds of playground, text playground, chat playground, image playground, because it is also having multi-model as well. So you can see here different model. Let's say you want to use this Amazon model. So just try to click here. See all kinds of Amazon model you will be able to see. It is having Titan text G1 Lite, Titan text G1 Express, okay, Titan image generator, then Titan multi-model embeddings. Now if you want to use, let's say, this model, what you can do, you need to just copy the model ID. So this is the model ID, and with the help of model ID you can use it. Similar wise for the meta also, let's say you want to access Llama, okay, Llama model, you can see. So for this you have to use this model ID. Okay, even from here also you can directly open in the playground and you can also play with these are the model. Even if you go to the example section, they have given different example. Even you can also copy these are the code and you can execute in your system. Now let's click on the base model. You can see different kinds of base model it is also having. Even if you want to train your custom model, it is also possible. Just go to the custom model. You can also perform the fine-tuning operation. So from the UI itself you can do the fine-tuning operation. Even let's say after fine-tuning you can also keep your model here, okay, in the custom model section, so that you can load this model as an API. Okay, every functionality actually this Bedrock will give you, so you can use them. So yes, this is the overview of our Amazon Bedrock. That means it's a platform, it's a LLM ops platform. Here we are having different kinds of foundation model. Even all the functionality it is also provides. With the help of these are the functionality you can create any kinds of GenAI based application. So in the next video, what we'll do, guys, we'll just try to do the hands-on on this AWS Bedrock. That means we'll be accessing these are the foundation model through the Python, okay, Python code. This video will be learning how we can, let's say, access this kinds of foundation model with our Python code. That means we'll be setting everything in our local machine. I will be writing everything from our VS Code. Okay, so what I will do, guys, I'll open up my local folder, and here I've already created one empty folder. Let me open up my VS Code. Okay, so I'm also going to open up my terminal here. And make sure you create one environment. So for me, I already created one environment. So let me activate. So conda activate LLM app. I think you remember this environment we created previously. So I'm using the same environment here. And you can see the Python version I'm using. It's 3.10. So you can use 3.9, 3.8. It's up to you. Okay, here the first thing you have to set up the requirements. So let me create a file called requirements. .txt. Inside that, let me mention all the requirements actually I need. So I need the Langchain. Then I also need Streamlit, because I'm going to create a small, let's say, user interface here. And I need two more library, Boto3 and Python.env. Python.env, I think you know why we need it, because we're going to create one .env file. Okay, .env file. So inside that you have to mention the your secret credential. That means we'll be generating access key, AWS access key, and AWS secret access key. With the help of that, we'll be authenticating with our AWS account. Got it? So we'll be keeping these are the key inside this .env file, and to load it, I need this Python.env. And what is Boto3? With the help of Boto3 Python package, we'll be making the connection with our AWS. Okay, so this library will give you the functionality you can connect with your AWS. Now let me set up everything in my environment. So I'll open it up. and just write pip install requirement.txt. Okay, for me it is already installed. For you it will take some time. Now the next thing what I have to do, guys, I have to create a IAM user. So let's go to my AWS. I'll go to the home page, and here you will see, or you can also search IAM. Okay, identity access management, because I have to create a user, and there actually I will only give the permission related my Bedrock. Now click on the user. Now just create a user here. I'll give, let's say, Bedrock test attach policy. Now search for Bedrock. I want to give the Bedrock, Amazon Bedrock full access. Now click on the next and create the user. Then after that, I will click on Bedrock test and go to the security credential. And here you will get one option, create access key. Just try to click here. Select command line interface. I understand, and click on the next. Now create the access key. Now, so guys, this is your access key and this is your secret access key. Now you can also download as a CSV file. Let me download. Now I have to configure it. So for this, you have to install one tool actually. So just search for AWS CLI. Okay, AWS CLI. This is the first website you can open. So for all the operating system, they have mentioned, okay, how we can install it. For Linux, Mac OS, okay, see, Linux, you have to execute some of the command. These are the command you have to execute. For Mac OS also, you have to execute some of the command. And for Windows, you are having one MSI file. So you can directly download this MSI file, and you can install, okay, as a software. That means the way you usually install any software. Now next, install, you have to do the same thing. After doing it, let me cancel it because I already have. After doing it, just try to open up your terminal, okay, and execute this command, AWS configure. AWS configure. Now see, if I execute, it should give you this kinds of window. If you are getting this kinds of window, that means your installation is fine. Now what I have to do, guys, I have to set these are the access key. Now just try to copy the access key. Open the terminal, and it is asking for the access key. Just try to paste. Just right click, it will paste, and press enter. Then you have to give the secret access key. Just try to copy. This is my secret access key, and I will paste it here. And don't share, guys, this key with anyone. Otherwise, they will be also accessing your account. I will delete it after the recording. And now it is asking for the region. Now you can see which region you are in. I'm inside Mumbai. That means AP South 1. So I have to give the region. So you just check which region you are working on. Based on that, you can decide. So AP South 1. Now default output format, just keep it empty. Press enter. That's it. See, my credential has been set. So this was the first method. And the second method, what you can do, you can, I think you remember we created this .env file. So here inside .env file also you can mention. So let me show you. So inside that you can mention AWS access key ID, secret key ID, and region name. So let me replace all of the secret key again. This is my access key ID. And this is my secret access key. And AP South 1, it's fine. Now let me save. Now here I'm going to create a file. I'll name it as main.py. Inside that I'm going to do the coding. So here, first of all, let's import some libraries. So these are the library I need. Let me select my environment. LLM app I'm using. Now here you can see, guys, I'm importing Bedrock from Langchain. Langchain.llms Bedrock. I'm importing Bedrock. Then LLM chain, then prompt template, Boto3, and Streamlit. Okay. Then I need another package, this one actually, .env, because I want to load these at the credential. And how to load, guys, I think you remember. So you have to use this code snippet. So load env, and you also need operating system. With the help of operating system, we'll be loading these are the key, okay, from the environment variable. Now here it will store everything. Now, if I want to initialize Bedrock client, so I have to use Boto3. So this is the syntax. If you go to the documentation, you will see that they're using this syntax. Bedrock client, you have to make a Bedrock client. The Boto3 client, you have to mention the service name. I want to use Bedrock. Okay, Bedrock services. That's why I've given Bedrock runtime. You have to give the region, AWS access key ID, and secret key ID. So with the help of that, it will authenticate with your account. Okay, I hope it is clear. Now, the next thing, you have to give the model ID, like which model you want to access. I'll give the model ID is equal to, let's say I want to use one foundation model. Let's say I want to use this Mistral model. I'll click on Mistral. Now you can see Mistral having different variants, 7B, 8X, 7B, then Mistral large. Now let's say I want to use 7B instruct. So what I will do, I'll copy this model ID. So that's how. Just try to open any kinds of model and copy the model ID. And here you just need to mention it. That's it. Okay, so it will automatically load this model. Now let's create our LLM wrapper. So inside Bedrock, you have to give the model ID. Okay, and here you have to give the Bedrock client. Okay, client is equal to Bedrock. Fine. And this is the temperature parameter. That means the creativity parameter. I think you already know. Now here I'm going to create a function. So this function will take the input from the user, like in which language they want to, let's say, get the output, and what is the input prompt. Okay, so this function will take this input, you can see language as well as the user text. Then it is create. Then inside that I'm creating a prompt template. I think you know what is prompt template, right? So this is the input variable, language and user text, and I'm creating a prompt template. You are a chatbot and you are in this language and this user text. Now based on that you have to give me the response. Now here I'm creating a LLM chain and I'm passing my LLM as well as the prompt. And finally, I'm passing my language as well as the user input to my Bedrock chain. That means the chain I actually have created. Okay, because inside that I'm having my large language model as well as the prompt. And whatever response I'm getting, I'm just returning. That's it. Now let me create a Streamlit title. Streamlit, let's say user interface, Bedrock chatbot demo. Now user will also able to give the language. So let's say here I'll take a language input from the user. Whether he want to get English response, Spanish response, or Hindi response, you can. So here you can also pass any other language. It will also work, because I think you know these kinds of large language model can also support multi-language. Then this is my final logic. So if language is there, so they will give the input. That means what kinds of question they want to ask. Then once they have, let's say, given the prompt, this particular prompt I'm checking first of all this they have given the prompt or not. If they have given, I'm passing it to my chatbot. You can see this function. So it will take the language as well as the user input. Language and user input, and whatever response actually I'm getting, I'm writing in my Streamlit application. Now let me execute and let me show you. I'll save it. Now simply I'll just open up my terminal, and this is the command Streamlit run main.py. So this is the interface, guys. Now you can select the language. Let's say I want to select the English. Now here I can ask any query. Let's say, what is Python? Now you just need to press you just need to press Ctrl and Enter. So guys, as you can see, if you give any kinds of prompt, now here is the response. So here I've given what is Python, and here is the response I got. Now I can ask any kinds of query. Let's say I will ask, give me a Python code to add 2 numbers. See, here I got the Python code to add the 2 numbers. Okay, so that's how you can pass any kinds of prompt and you can get the response. It's amazing, guys. And here we're using Mistral model. Okay, Mistral model we are using. Okay, and it is present inside Bedrock platform. That's why this inference time is very low. You will see that I'm getting very fast response. But whenever I was using Mistral model, I think you remember in Hugging Face. Okay, Hugging Face Hub. So there I had to download this model in my system, and the execution time was like very slow there. Yes or no, right? So that's why we have to use this kinds of LLMs platform if I'm implementing any kinds of project, efficient project, okay, in the industry. So yes, guys, now you can explore different kinds of model, different kinds of like foundation model. You can also explore coherent model, meta model, anything you can explore. Only just need to keep the model ID and everything you can access. Got it? So yes, guys, I hope it is clear now how we can use this Bedrock platform. And if you want to get this kinds of content more, so please try to support our channel. So please try to subscribe to the channel, try to share this kinds of content with your friends and family so that they can also get to know, okay, this kinds of session is going on. So please try to support the channel, guys. Try to like the video, try to subscribe to the channel. You can subscribe to the Code Commander channel. Even you can also subscribe to my channel, DS with Bappy. Okay, both channel actually I'm operating. You will see that in both channel I'm creating lots of content related data science, machine learning, generative AI, ML ops, okay, end-to-end project implementation, okay, everything I'm creating the content. If you don't know what is AWS Bedrock, AWS Bedrock is a platform from Amazon Web Service. We can use this particular AWS Bedrock to create a scalable generative AI application with the help of large language model. So if you want to use this particular platform, Amazon Bedrock, so you should have one AWS account. So for me, I already have the account. So
So if you don't have any account, so please try to create one AWS account, then you will be able to access this particular platform. Now, if you can't see this particular service here, so what you can do, you can search here called Bedrock. Okay, if you just search for Bedrock, so you will get this particular service called Amazon Bedrock. Now let's try to click here. So it will launch this particular platform for you. See guys, so this is the Amazon Bedrock platform, and this is the easiest way to build and scale generative AI application with the help of foundation model. So it is having lots of foundation model. I'll tell you what are the models actually it is having. So it has one beautiful documentation. You can go through this particular documentation, like what it can perform and all. So you can perform text generation. You can also create chatbots. You can also perform the search operation, text summarization, image generation, and personalization. Okay, so this many tasks actually you can perform here. And these are the actually foundation model. So it is having, let's say, lots of model. It is having Jurassic 2 model, Cloudy model, Command, Stable Diffusion, and Amazon Titan. And you have another model called Llama 2. Okay, Llama 2 is a model actually from Meta AI. So this is one of the like very popular and powerful model. Okay, you can use. So in this particular project, actually, I'm going to use this particular Llama 2 model. Okay, and I will also use any other model to show you like how we can access this particular Bedrock model. Okay, from the Bedrock platform. Now what you have to do, you have to click on this particular get started button. So if you just click on the get started button, okay, so initially it will tell you just try to request for the model. Okay, request to access all the model, because if you're using for the first time, you have to send a request like to access all the model. Okay, so I already made the request and I already got the permission, and I can access all the model, okay, from this particular platform. Now guys, as you can see, so in the overview section, so these are the models are available. Now let's say if you want to use this particular model, Jurassic 2 model, just click on this particular model. Now if you see, Jurassic model is having different variant. Okay, so it is having Jurassic 2 Ultra, and it is having another model called Jurassic 2 Mid. Okay, you can either use this mid model, either you can use this Ultra model. Okay, so similar wise, if you are using, let's say, Amazon, okay, so it is having different model. So it is having, let's say, Amazon this Titan embedding G1 text model. So this is the embedding model. Then it is having Titan text G1 model, light model. Then Titan text G1 express model. Okay, that's how it is having different model. Even it is also having Titan image generation model. Okay, that's how actually, let's say if I click on Meta, okay, that means Llama 2. So it is having different variant of the model Llama 2. So it is having Llama 2 chat 13 billion model. It is having Llama 2 chat 70 billion model. Even it is also having Llama 2 13 billion model and 70 billion model. Okay, so these are the pre-trained model and these are the chat model. Let's say if you want to perform question answering and chat operation, you have to use these are the model. And let's say if you want to only generate, let's say, a text, and if you want to, let's say, do the sentence completion, at that time you can go with this particular model. Okay, so that's how actually it is having different model. Okay, based on the base model actually you can see here. So again, I will go to the overview. Now you can see I already showed you the foundation model. Now it can perform different tasks. I already showed you. Let's say you want to do any example, so you just go to the example section. Now here you can select what kinds of tasks actually you want to perform. So here you can see different tasks. Even it is also having the playground. Let's say I will open this particular playground. Okay, so playground, I want to perform, let's chat operation. So now here what I have to do, first of all, I have to select the model I want to use. So let's say I will be using this particular model called Jurassic 2 Mid model. So I'll select this particular model and apply. Okay, after that I will get this kinds of interface. Now here you can give any kinds of prompt. Let's say if I give hello. So here, let's say if I send hello, okay, to this particular model, so it will give me the response. See, it is also responding like, hello, how are you? How I can help you today? That's how actually you can also change the temperature parameter, topic parameter. Okay, so these are the parameter you can change. So what is the temperature parameter? Temperature parameter is a creativity actually parameter. So let's say if this temperature parameter is like, let's say, close to 0, that means you are telling your model to be stick. Okay, it won't be taking any risk. And if you are setting this parameter to close to 1, that means you are like telling your model just take any risk. Okay, and try to give a creative output. So that's actually you can change these other parameters. So by default you can, so by default just keep this default parameter only. Now you can give any kinds of prompt here. Okay, it will respond with respect to that only. Now guys, this is for the playground. Okay, but whenever I will be creating the application, I'm not going to use this particular model like that. So I have to use this particular model, okay, with the help of this Python programming language. So with the help of Python client, actually we'll be accessing this particular model. But how to access this particular model, because this model is already available in the AWS. Okay, so how to authenticate with this particular account. So for this, first of all, you have to create one IAM user. Okay, so first of all, let me create one IAM user, and let me like add this particular secret key and access key. Then I'll tell you how we can access this particular foundation model, okay, from the AWS Bedrock. So guys, as I already told you, to authenticate with this particular AWS, and if you want to access this particular Bedrock services and all, so you have to first of all create one IAM user, and you have to collect that particular access key and secret access key. Okay, then you have to configure that.
So for this, you have to search for this particular service called IAM. Okay, that means Identity Access Management. Now here I'll go to the first option, IAM. Now left hand side, you can see there is a user option. Okay, let's click on the user. Now here I'll be creating one user, create user. Just give the name. So here is, let's say I'm doing a Bedrock project. So I'll just give it as Bedrock user. Okay, then I'll just click on next. Then I will be adding the policies directly. So here you need to select this particular option. Now here you have to search for the Bedrock service, okay? Because I want to only give the Bedrock access, okay? Not the entire service access, okay? From my AWS account. Now here if you see Amazon Bedrock full access, okay? So I'll select the first option, then click on next. Then once it is done, I will just create the user. Now my user has created. Now I'll go to the user. I'll go to the security credential. And here you will see something called create access key, okay? Let's click on the create access key. Now I'll select on the command line interface. Then I understand the above recommendation, then click on the next. Then once it is done, I will create the access key. Okay, now see guys, this is my access key and this is the secret access key. And don't share this particular credential with anyone else, otherwise they will also able to access your account. Okay, I'm sharing because I'm going to delete this particular user after the recording. Okay, that's why I'm showing. Now what I have to do, I have to download this thing as a CSV file. So click on this particular button. Okay, it will download as a CSV file. Okay, see, I've already downloaded. Now if you want to authenticate, okay, if you want to authenticate with your actually code. So what you have to do, first of all, you have to install one tool, okay, called AWS CLI, okay, AWS CLI download. Just search on Google AWS CLI download. So this is the website actually you will get, and you have to install this particular tool. Now you have different operating system. Let's say if you're using Windows, so you will get one MSI file. Okay, as you can see, this is a MSI file. So try to download this particular MSI file and try to install it the way actually you do install any regular software. Okay. Then if you're using any Mac OS or let's say Linux operating system, you can follow these are the command to install this particular AWS CLI. So here I'm using Windows machine. So I already downloaded this particular MSI file. Okay, let me show you. So this is the MSI file. So inside Windows, so this is the MSI file. If I click here, so it will start download. See guys, it will start download. Okay, now I'll cancel it. Okay, after downloading, you have just need to double click and you have to install as a regular software. Okay, then once it is done, then I will open up my terminal. So first of all, let me open up my local folder. Okay, so this is my local folder. So here I'm going to open up my terminal. Okay, but before that, let me create one folder here. So inside that, I'm going to do my project. So here I'm going to name this particular folder as Generative AI application. Okay, Generative AI. Generative AI project. Okay, Bedrock. Let's say this is the name. Now inside that, I'll open up my terminal. Okay, so let's open up my terminal. Yeah. So now here, what you have to do, first of all, you have to test this particular AWS CLI, whether it has downloaded successfully or not. So for this, you just need to execute this particular command called AWS, okay, configure. So if you execute this particular command, so it will give you this kinds of interface. See, it will give you this kinds of interface. And if it is not giving this kinds of interface, if it is throwing any kinds of error, that means you are not able to install successfully. Okay, you have to install it successfully. So for me, I already installed successfully. That's why I'm getting this particular option. Now here you have to provide that particular credential. Okay, that AWS secret key ID you have downloaded. Now let's go back to the CSV file I have downloaded. So this is the CSV file. Let me open it up. So guys, I already opened up this particular file with the help of my Notepad++. Now, as you can see, this is the access key ID. Now you have to copy before the comma because this is the comma separated. This is a CSV file. So I'll copy this particular credential and I'm going to open up my terminal and I'm going to paste it here. Okay, so just right click and paste it. Okay, so it hasn't copy yet, I think. So I'll copy again. I'll open up the terminal and let me remove. Now I'm going to paste. Okay, now see, if you right click, it will paste. Now if you hit enter, it will automatically save. Okay, now you have to also set for the AWS secret access key. Okay, so this is the secret access key. So copy before the comma and again open up the terminal and paste it here. Okay, then it is telling select the region. Okay, so make sure you are checking the region currently, which region you are in. So for this, just go to the home. Okay, AWS home. So here you actually will see that particular region. Okay, see, now currently I'm inside North Virginia. That means US East 1. Okay, but if you're in any other region, you have to select this particular name. Let's say you are inside Asia Pacific. That means Mumbai. You have to write AP South 1 that time.
but I'm inside US East 1. Okay, that means not Virginia. So I'm going to write US East 1 here. So I'll be opening the terminal, and here you just need to write in the same way US East 1. Okay, now I'll press enter. Now you have to keep it as default, press enter. Now see, all the credentials has been set. Now I can easily authenticate with my Bedrock, okay, Bedrock platform with the help of this particular terminal. Okay, now what I have to do, so let me open up my folder, the project folder I have created. Now inside that I'm going to open up my VS Code. Okay, so let's open the VS Code. So here let me write down all the steps so that you can refer later on also. In the readme file I'll add everything. So here let me close it. Now first of all I'll create a file called readme. Okay, readme.md. So here first of all let me give the project name. So this is end-to-end, okay, end-to-end generative AI project, okay, using AWS Bedrock. Okay, so this is the title of my project. Now inside that I'm going to write the step, okay, you have to perform to set up this particular project. So first of all you have to create one virtual environment. So I already written, so let me just give it here. So these are the steps I have to perform, okay, if I want to execute this particular project. So first of all I have to create one, okay, I have to create one virtual environment. So let's give the name. So this is, let's say, Bedrock project. Okay, so Bedrock okay, Bedrock project, Bedrock project. Now you have to activate this particular Bedrock environment, okay, you have created, and make sure you are using Python 3.8. You can also use more than Python 3.8, it's completely fine. Then you have to install the requirements, because I'm going to write some requirements, okay, for this particular project. You also need to install them. Then I already told you have to download this particular AWS CLI, okay, and this is the link I have already given. Then you have to set up it, okay. After setuping, you have to configure that and add all the credential, okay. So these are the steps actually you have to perform. Then what I will do, I'll quickly create some of the folders and file here. So first of all, I'm going to create a folder called research. Okay, research. Inside research, I'm going to create one file called trials. Okay, I can write bedrock trials. Okay, bedrock underscore trials dot file. Then outside, I'll be creating another file called main.py. Okay, then I'm going to create a requirements file, requirements, okay, .txt. Yeah. So as of now, I need these are the folders and file. If you want to add like git ignore and license file, you can add it. If you want to commit this particular code in the GitHub, but I'm not going to commit. Okay, so that's why I only need these are the files and folder. Now, first of all, let's add all the requirements actually I need for this particular project. So first of all, let me show you what are the tools and technology I'm going to use. So for this, I'm going to open up my Blackboard. So here, I'm going to use some of the tools. Okay, so the first thing I'm going to use Langchain. Okay, I think you already know what is Langchain. Langchain is a generative AI framework. Okay, so we can use this particular Langchain to create generative AI application. Okay, so it is having different functionality. So it will help you to create that particular application. Okay, so then second I need something called PyPDF. Okay, PyPDF. Why I need PyPDF? Because I'm going to upload my PDF data. Okay, and from there actually I'm going to do the retriever operation. Okay, that means query operation. I'll tell you like what kinds of application we're building. Okay, so we'll be building something called RAG application. So there actually we'll be creating one knowledge base. Okay, with the help of custom data actually I'm giving. So that's why my data source would be PDF data. You can also use docs data or txt data. It's completely fine, but I'm going to use PDF data here. So I'm going to like also show you the architecture. Okay, architecture of this particular project, like how everything will work. But before that, let me write down the tools and technology I'm going to use in this particular project. Then I'm going to use something called Streamlit. Okay, Streamlit. So Streamlit I'm going to use to create the user app. Okay, because I'm going to create a user app. So that actually user will get some interface to use your application. So for this, I'm going to use Streamlit. You can also use Flask, okay, First API, or any other, let's say, web framework. It's completely fine. But Streamlit would be easy for me to, like you can say, implement, because there I'm not going to write any HTML and CSS code. Okay. Then after that, fourth, I'm going to use VectorDB. So VectorDB wise, I'm going to use files. Okay. So FICE. So FICE is a vector DB. So this is for Facebook. Okay, Facebook team has developed this particular vector DB called FICE, and this is the local vector DB. Okay, you can also integrate Pinecone, then Weaviate, ChromaDB. Okay, it's up to you. But I'm going to use FICE. So in future, maybe we'll be creating some other projects. So there actually we can use any other vector DB. Okay, so these are the tools and technology I'm going to use for this particular projects, and definitely the final tool and platform I'm going to use something called Bedrock. Okay, Bedrock from the AWS. Okay, so Bedrock I'm going to use, and LLM wise I'm going to use something called Llama 2. As I already told you, I'm going to use Llama 2. Okay, from Meta AI. So this is the LLM I'm going to use. So yes, so this is the tools and technology I'm going to use. Now let me quickly install these are the tools and technology. So what I will do, I'll open up my code, and here let me write down everything one by one. So first of all, I need something called Langchain. Okay, Langchain. Then I need something called PyPDF. PyPDF. Then I need something called Streamlit. Okay, then I need something called Fire CPU. Fire CPU. Okay, so let me save it. Now, first of all, I need to create an environment. So I'll copy this particular command, and I'm going to open up my terminal, and let me create this particular environment first of all. So guys, as you can see, my environment is created. Now I have to activate. So this is the command on the activate. So now let's activate also. Now see, I'm inside this Bedrock project. Okay, that means this particular environment. Now I have to install the requirements. So for this, I'm going to execute this particular command. See, now it is installing everything. So it will take some time. Okay, so let's wait. I'll come back once it is done. So guys, as you can see, installation is completed. Now what I have to do, yeah, so now I can start the coding part. So yeah, so make sure, yeah, so now what I will do, I'll go inside this particular resource folder, and first of all, I will test this particular Bedrock. Okay, like how we can connect this particular Bedrock and how we can access the model and all, because I already showed you it is having some foundation model. And if you want to access it, so for this, first of all, you need to do some authentication. So that authentication we have already completed. So let's go inside this particular Amazon Bedrock. Yeah. So now see, these are the models are available. Okay. And I think you already know this Llama 2, then Mistral. So these are the model is also open source model. Okay. So this model is also available in the Hugging Face. Okay. Hugging Face is also having, these are the model. Let's say I want to access Meta Llama model. Okay. So this is the model actually I can see. So all the model actually you have 7B, then 70B, 13B, all the model actually you are having. But if you want to load this particular model, okay, you have to download this particular model from the Hugging Face itself. Okay. For this, you need GPU machine. Okay. You need a GPU machine, and you should have a good memory there. Okay, otherwise you can't actually load this particular model. Even if you have already used this particular model, okay, so you'll see like inference time would be also high because it's a huge model again. Okay, because everything you are running on your local machine. Okay, and then you are executing this at the model. But whenever I'm talking about this particular Amazon Bedrock, so this model actually is already hosted here. Okay, as an API, so you can connect this model through API. Okay, API request. So first of all, you just need to make a client. Okay, with the help of this particular client, you can send a request. That means you can send a prompt and you can get a response, okay, from this particular model. And this execution time would be very fast. Okay, so for this, if you want to, let's say, create a production grade application, and if you want, let's say, faster inference, okay, at that time you can go with this particular Amazon Bedrock service. Okay, but let's say you have a good instance. Okay, you have a good instance, you have lots of money, you can buy good instance, good GPU configuration machine and all. And if you are not worrying about the faster inference, at that time you can go with these are the model. Okay, you can like manually download this particular model and you can use it. But here we'll be using the client, okay, to access this particular model. And every request actually will be sending, okay, will have some of the cost. Okay, now if you want to check the cost also, so you can check it out. Let's say if I want to use Llama model, so Llama is having their like cost, okay, cost per request. So here you can see the view pricing option. So per token actually it will charge you. Okay, so see, so if you're using this model, Jurassic to mid model, so let's see the Llama model. I think Llama model is also there. Yeah, Meta Llama. So this is the price per 1,000 tokens. Okay, see, per 1,000 tokens, this is the price actually it will charge. It's like very less. Okay, lesser than your OpenAI, I think. Okay, so there is no like more charts, so you don't need to worry about. So if you want to create a production grade application, so you can go with this particular Amazon Bedrock service. Okay, you can visit that particular pricing page and you can try to understand. Now what I have to do, guys, first of all, let's try to access one particular model, okay, from this particular Amazon Bedrock. So let's say I want to access this particular model called this Jurassic model. Okay, so Jurassic model I want to access. Let's say I want to access this particular model, Jurassic mid model. So if I want to access this particular model, I have to hit the API request. Okay, so here I have to send the API request, but I'm going to send the API request throughout the Python. Okay, so guys, now let's see how we can use this particular Amazon Bedrock. That means the different actually foundation model. Okay, so first of all, we'll be doing this particular experiment, and if we are able to access this at the model, okay. So next, actually, I'm going to show you how we can create this particular end-to-end RAG application with the help of this particular Amazon Bedrock. So I'll go to my code editor, and first of all, here I'm going to import this Bedrock from the Langchain, because it is already available in the Langchain, okay, Langchain framework. So we have already installed this particular Langchain. So make sure you have selected the correct environment. So let me refresh. So this is the environment I'm using. Yeah. So Langchain dot you have to import LLMs. Then inside that you have something called this particular service called Bedrock. Now I'm going to import this particular Bedrock class. Okay. So Bedrock. Then I also need something called LLM chain, because here whenever you will be creating that particular QA object, okay, so you need this particular LLM chain. So let's create this particular LLM chain. So from Langchain dot chains. So if you already know about Langchain, I think you already know what is the things actually I'm importing, because these are the requirement actually I'm expecting you are already familiar with this particular Langchain framework. Okay, so chains, I'm going to import something called LLM chain. Then I'm going to import something called prompt template. So here I'm going to write from Langchain dot prompts. Okay, I'm going to import something called prompt template. Then I'm going to import another library called Boto3. Okay, so if you don't know what is Boto3, Boto3 is a library, Python library actually we can use to connect with our AWS account. Okay, but here we haven't installed this particular package, so let me install also. So here I can write Boto3. Now let me open up my terminal. Now again I'm going to install this particular requirements. So installation is completed. Now let's create the client quickly. So with the help of this particular client, actually I'll be accessing the Bedrock. So we have imported Boto3. Then I also need to import Streamlit, okay, because I'm going to create one basics UI for my user. Okay, so that's why it's needed. So let's import it. So import Streamlit as ST. Yeah. Okay, it should be import, okay, not from. Yeah, now I think everything is fine. Now, first of all, I'll be defining the Bedrock client. Okay, so let's define the Bedrock client. Bedrock client. So for this, I'm going to use this particular Boto3. So Boto3, okay, dot client, and here you have to mention the service actually want to use. So service underscore name. So I want to use this particular Bedrock service. Okay, so you have to write Bedrock underscore runtime. Okay, Bedrock underscore runtime. Then you also need to define the region, like which region actually you want to use in the AWS you are having. I already told you how to check the region. So we are inside this particular US East 1. Okay, so let me also write down this particular region. So I'm inside this US hyphen East hyphen 1. Okay, so this is the region. So yeah, guys, this is my client. So I'll store this particular client in a variable. So let's name it as Bedrock. Okay, Bedrock client. Then I need to write the model ID. Okay, which model actually you want to access from the Bedrock. Okay, so you have to define the model ID. Now how you will get this particular model ID? So again, go back to this particular Bedrock, and I already told you it is having different foundation model. Let's say I want to use this particular Jurassic 2 model. Okay, I'll click here. Now it is having different like variant, Jurassic Ultra and Jurassic Mid. Let's say I want to use this particular Jurassic Mid. I'll click here. Now if you just go below, this is the model ID. Okay, now let's copy this particular model ID. I'll copy and I'll open up my code, and here I'm going to paste it. Okay, so this is the model ID. Now here what I have to do, I have to create a LLM wrapper. So let's create a LLM wrapper. LLM is equal to Bedrock, and inside that, first of all, you have to define the model ID. Okay, model ID So model ID means the model ID actually we have defined. Okay, this particular model I want to access. Then after that, I have to also define the client. Okay, so client is equal to this Bedrock client we have created. Okay, with the help of this Bedrock client, it will authenticate. And how it will get this particular credential? I think you remember we already set those credential, okay, in the terminal by running that particular AWS configure command. Okay, so it will take the access key and secret access key from there, and it will take by this particular library called Boto3. Okay, Boto3 automatically will take take this particular credential, okay, from the environment. Then what I have to do? I have to define the model keyword. Okay, so let's define the model keyword also. So model arguments. So inside that, I'm going to mention one arguments called temperature parameter. Okay, because this is the parameter we usually tweak a lot actually whenever we are using LLM and all. Okay, so here is the temperature parameter, but it should be defined as a string, right? Then here you have to provide the value of this particular temperature parameter. So let's take 0.9. That means I'm taking close to 1. I'm telling my model just take any risk and try to give a creative output. Okay, whenever you are generating any kinds of let's say output and all. So you can set this particular parameter based on your requirement. So I set 0.9. Now what I will do, I'll create a function here called my chatbot my underscore chatbot. Okay, my chatbot. So inside that, actually, I'm going to write the final logic. Okay, so it will take the language. I also want to give the language. Okay, language. Let's say choice. Let's say you want to generate this particular response in English language, or let's say Spanish language, or let's say Hindi language. Okay, you can give any kinds of language. So you can give this particular parameter as language. Then it will also take the user. Okay, user text. User text, like whatever text user is giving, it will also take that particular input. Then what I have to do, I have to create a prompt template here. So prompt template, I have already imported this particular prompt template. Now inside prompt template, first of all, I need to specify the input variable. Okay, so input variables. Okay, so here input variables, I'm having the language. Okay, language and this user text. Okay, these two actually, I have this input variable. Okay, here. Now what I have to specify, I think I should also close this particular quotation. Yeah. Then I also need to specify my actual template. Okay, so the template is equal to, so here you can give any kinds of, let's say, prompt. So I'll give this kinds of prompt actually. So you are a chatbot, you are in this particular language, and this is the user text. Okay, so this is the prompt I have given to my LLM. Okay, that's how you can define this particular prompt template. Now let's store this particular prompt template in a variable. I'll just name it as prompt. Okay, prompt. Now what I will do, I'll just create a LLM chain. So LLM chain is equal to, I'll define this particular LLM object. Okay, LLM is equal to the LLM wrapper we have created, LLM. Then I also need to give this particular prompt. So prompt is equal to, okay, prompt is equal to prompt we have created. Okay, then I'll store this particular things in a variable. I'll just name it as Bedrock. Okay, Bedrock underscore chain. Now user will ask the query and they will get the response. So for this, I'm going to utilize this particular Bedrock chain I have created. So Bedrock chain. So it will take first of all the language. Okay, input as a language, because first of all user will give one language, so it will take that particular language. So language should be language. Okay, then it will also take the user input, user text. So user text should be user text. I think everything is fine. Let's test. Okay, it should be text. Okay, not a test. So that's why this error is coming. User text, and now I think everything is fine. Now the response actually I'll be getting, so it will return me the response. Okay, so I'll return this particular response. So return this response. Yeah. Now this function is ready. Now I can inference on top of the model actually. I'm using here. Now what I will do, I'll create a basics Streamlit. You can say UI. So for this, first of all, I'll give one title, so st.title. So here you can give any name of the application. So here I can write Bedrock. Okay, Bedrock demo or Bedrock test. Okay, Bedrock bedrock test. I can just write. Then first of all, I'll be taking one, you can say select box here, because user will, you can say, choose the language. So for this, you can use this particular code snippet. So see, here I'm creating one like select box, and user will select the language. So here you can add as many as language you can. So I have only added 3 languages: English, Spanish, and Hindi. Okay, you can also add Bengali. Then you can also add, let's say, I mean, like Russian. Okay, anything you can add here. It's up to you. Now what I will do, I'll just write one logic. If user is given any kinds of language, so what you have to do, first of all, you have to take the input from the user. So I'll take this input and I will store in this particular variable user text. Okay, user text is equal to, so here I'm going to create a select text area. Okay, because I'm going to just create a box. Inside that particular box, user will give the input. Okay, so for this you can use st.sidebar. Okay, then you can take something called text area. Okay, text area. Yeah, then inside that you can define the label. That means the quotient actually you want to render here. So I'll give a message, what is your, okay, what is your question. Okay, and you can also define like how many, let's say, character user will able to put. Okay, so here you can just define max character is equal to, I will just specify 100. Okay, so 100 character user will put here. Then once it is done, so I also need to check this user text. That means if user has given any kinds of input text, that means the prompt, okay, to the LLM. So what I have to do, first of all, I have to give it to my model. So I'll call this particular function my chatbot. Inside that, first of all, I'll give my language. Okay, the language user has selected. Then I will also provide something called user text. Okay, whatever question actually user is asking, then it will give me the response. Okay, so it will give me the response. Yeah. Then after that, I will write this particular response in the Streamlit. Okay, Streamlit application says t dot write, and here I'm going to write this particular response. So I'm going to only extract the text, okay, from the response. So it should be text. Yeah. So I think it should work. Now let's test whether it is working or not. So I'm going to open up my terminal. So let me create this particular terminal, and I'm going to execute this particular file, this bedrock trials.py. So for this, you have to execute this particular command. Okay, so let me also add this particular command. So if you want to execute the file, so you can write streamlit. Okay, streamlit run. This is inside resource. Okay, slash. The name of this file is bedrock trials. Okay, .py is the name. Now let's copy the command. I'll open up my terminal and let me execute. Okay, so it is giving one error. It is telling research. Okay, so research spelling is not correct. Let me check. So research. Okay, now I think it's fine. Now let me copy and execute. Okay, now my application is running. Now if I go to my browser, now if I open up my browser, okay, so it will open up one new tab. So this is the tab it has opened, but again I can see there is an error. So what is the error? So unknown service error. So unknown service bedrock underscore runtime. Okay, so let me check this particular code snippet. So here, okay, so it should be bedrock hyphen runtime. Okay, not a underscore runtime. Now I think it should work. I'll go back and rerun this particular application. Okay, now see, this is my interface. Now you can select any kinds of language. So let's select the English language. Now ask any kinds of query. So I'll ask what is, okay, what is let's say what is C++. Okay, what is C++? So now let's see whether it is able to give me answer or not. Now if you want to execute, you need to press Control and enter. So here it is giving me the response. C++ is a general programming language. That means yeah, so it's a correct response. Now you can ask any kinds of query. So you can ask like what is Python, okay, and Control enter. See, it is also giving the response. Now see guys, although I am using this particular model, okay, this large language model, and I'm also using this open source model, okay, Jurassic is also open source model, but the response time is like very first here, because this model is already hosted, okay, over the Bedrock, and we can access this particular model with the help of this particular client. Okay, the client actually you have created. Okay, this particular client we have created. Okay, so that is why actually whenever you want to create any kinds of production grade application and you want to, let's say, get a quick response, at that time you can go with these are the services. But whenever, let's say, you are loading these are the model on your machine, at that time your inference time would be very higher. Okay, like it will take lots of time to execute that particular code. So that's why actually you can use this particular Bedrock, and this is like very scalable. Okay, like it is like very efficient solution whenever you are trying to create any kinds of generative AI application. Now see guys, I already showed you how we can access different model. Now let's say you want to also access meta model. Okay, so what you can do, you can come to the meta and you can take this particular model ID. Now let's say you want to access this particular model, this 70 billion parameter model. So you need to give this particular ID. Okay, so here you just only need to change. So let me show you. If I open up the code, so here you only need to change it, okay, inside the model ID, and everything will remain same. But here only we're doing the inferencing, okay, on top of the model. But now what I'm going to do, I'm going to create one end-to-end RAG application. Okay, so end-to-end RAG, like you can say, project will be implementing. So what is RAG? So let me give you one idea. So first of all, I'm going to create a architecture, okay, of this particular project I'm going to develop. So here, first of all, what I'm going to do, as I already told you, I'm going to use PDF documents. Okay, let's say I'm having some PDF documents. Okay, PDF docs. Okay, so it can be multiple PDF also, it can be one PDF also, it's up to you. Now what I have to do, first of all, I have to extract the text. Okay, I have to extract, okay, extract data, okay, from this particular PDF. After extracting, what I have to do, I have to create a chunks. I have to create a chunks. Why I have to create a chunks? Because all the model is having their input length. Okay, if I show you, let's say I'm using this Meta Llama 2. Okay, going forward, I'll be using this Meta Llama 2. So Meta Llama 2 is having actually input size. Okay, this token input size. Let me show you. So if I go to the official Meta Llama 2 website, so let's go to the website. So here you can see, guys. So it is having different models: 7 billion, 13 billion, and 70 billion. And if you see here, the context length is 4096 token. Okay. Now what will happen? So whenever you are using any kinds of PDF documents, so if you extract all the data, that means all the documents, okay, from the PDF, you will see sometimes it would be more than 4096 token. Okay, it would be more than 4096 token. At the time, if you give this particular input to the model, okay, to the model, your model will throw input error. So to prevent this kinds of issue, what I have to do, I have to create a chunks. Okay, chunks means I have to create a different chunks. Okay, let's say this is your entire text. Okay, let's say this is your entire text. Okay, this is your entire text. So what he will do, he'll just take a chunks. Okay, chunks of the text. So this is one chunks. This is another chunks. Okay, this is another chunks. Okay, that's how you will be giving to the model. Okay, as input. So different chunks actually you are giving. Instead of taking all the text together, you are giving different chunks. So that time you have to also define the chunk size. Okay, and there is another parameter we can also define called chunks overlap. Okay, so this is the idea of this chunking. Now once this chunks is created, now what I have to do, I have to download one embedding model. Okay, I have to download one embedding model. So in this case, I'm going to use this Titan embedding model. I already showed you. Okay, so embedding model, Titan embedding model. With the help of this particular embedding model, I'll convert this particular data to vector embedding. Okay, so vector embedding. Vector embedding. That means numerical representation. Vector embedding. Then what I have to do, I have to store this particular vector embedding in a knowledge base. That means in a vector DB. So here I'm going to use something called FIAS. Okay, FIAS is a vector DB. It's a vector DB. Vector DB. Okay, so this is nothing but this is my knowledge base. Knowledge base. Okay. Now what will happen? User will ask some query. So let's say this is the user. So user will ask some query. So let's say this is the query user has asked. So what I have to do, I have to pass this particular query to my knowledge base. Okay. So it will do something called semantic search. Okay, semantic search, semantic index search. I think you already know what is semantic search inside vector DB. Then it will also return some of the rank results. Okay, it will return some rank results. Rank results. Okay, so it will return this particular rank results based on the k parameter. Let's say if k is equal to 3, so it will return only 3 relevant answer. Okay, with respect to the query you have asked. Now what I have to do, I have to connect the LLM. So I'll be collecting the LLM. So in this case, I'm using something called Llama 2. okay, Llama 2. So I'll feed this particular ranked results to the LLM, okay, then I'll also give the query to the LLM. So LLM will try to understand the query, it will also try to understand the results, that means the answer. Then it will process this particular query answer and it will give you the actual response, okay, actual response. So response. Okay, so let's say you have asked something related Python. So first of all, it will check in the knowledge base whether I am having answer related Python or not. If it is having, so it will take most relevant 3 output, okay, from this particular knowledge base. Then it will process, okay, based on the query, then it will give you the correct response. That means what is Python exactly. Okay, this is the idea. And this is called, okay, this is called RAG application, okay, RAG pipeline. This is called RAG pipeline. Okay, this is called RAG pipeline. That means retrieval augmented generation. So instead of fine tuning the model, what I'm doing, I'm just adding some additional knowledge, okay, additional information in, okay, information, okay, additional information to the model. Okay, so this is my additional information. So I'm just processing this information, I'm creating the embeddings, okay, and I'm storing in a knowledge base, and I'm connecting, okay, I'm connecting the LLM to the knowledge base, and whatever is user is asking this kinds of query, okay, I'm just like getting the response and I'm showing to the user. Okay, so this is called RAG pipeline. And what is fine tuning? Fine tuning means whenever you will be like say training that particular model, that means you will be changing the weight parameter. That is called actually fine tuning. And fine tuning is like very hard task and it's like very costly task. Okay, so that's why you don't need to perform this fine tuning every time. Okay, first of all, you will be applying this particular RAG concept, and if RAG is working fine, then you will be going with the RAG concept. And if RAG concept is failing somewhere, that time actually you have to perform the fine tuning. So in future actually we'll be also learning how we can perform the fine tuning, okay, on top of the custom data. That thing we'll be also learning. So yes guys, this is the entire architecture of our, like you can say, application. Now I need to code this particular example. So for this I'm going to again open up my code editor. Now here I'm going to open this particular main.py file. So guys, I think you already got the idea how things are working and how we can make the connection with this particular Bedrock and all. So let me just quickly write all the code. So first of all, I need to import some of the library here. So let's import all the library. So these are the libraries are required. Okay, so I'm importing Boto 3 because of that particular, you can say Bedrock. I want to access with the Bedrock. Streamlit I need because I'll be creating the web application. Then I'm also importing something called Bedrock embedding. Okay, because I already told you I'm going to use one embedding model. Okay, from the Bedrock. So Bedrock having also embedding model. So if I show you, let's say Amazon is also having one model called Amazon Titan. Okay, so let me show you. Yeah, Titan embedding G1 text. Okay, this is the model. So this embedding model actually I'm going to use. Okay, that's why I'm importing this particular embedding from the you can say Langchain. Okay, and this is the Bedrock embedding. Then I also need this LLM, that means Bedrock. Then PyPDF directory loader because I'm going to keep some PDF, okay, in the directory. So let me create a directory here. I'm going to name it as data. Okay, and I can name it as PDF data. Okay, PDF data. Inside that I'm going to keep my PDF. So with the help of this particular package, I'm going to load this particular PDF. Then recursive character text splitter. So I already told you something called chunkings. So if you want to perform the chunkings, you have to use this particular method called character text splitter. Okay, recursive character text splitter. Then I also need something called vector-DB. So vector-DB wise, I'm going to use Fires, and it is already available inside Langchain. And prompt template and retrieval keyway because I'm going to perform. Then I'm importing this particular retrieval keyway. Okay, this particular method because as I already told you, I'm going to create this RAG application, and on top of the knowledge base, actually I'll be performing the query operation. Okay, so that's why actually this is needed. Now the first thing what you have to do, you have to define one prompt template. Okay, so this is the default prompt template I just prepared. Okay, so here I've just written. So a human will ask some query. Okay, based on that you have to return the response. Okay, by taking the context. Okay, context means the knowledge base. So this is the prompt template I have created. Now what I have to do, you have to connect the client. Okay, so I think you know how to collect the client. So this is the code for the client. So Boto 3 client, and you have to provide the service name and the region name. Then what you have to do, you have to get the embedding model. So to get the embedding model, what you can do, you can use this particular Bedrock embedding. Okay, Bedrock embedding to load the embedding model. So here is the code. Okay, so that's how you can load this particular embedding model. As you can see, Bedrock embedding. Here you have to give the model ID. So Amazon Titan embed text v1. So this is the model actually I'm using. So Amazon Titan embed text v1. Okay, so this is the model ID I'm using. Let me show you. Yeah, so this is the model ID. After that, you have to also assign the client. Okay, the client actually you have created. Then first of all, what I have to do, I have to load this particular PDF documents. Okay, so I don't have any PDF, so let me upload some of the PDFs here. So I'm going to open up the folder, and here I'm going to keep this particular PDF. Okay, so this is one research paper actually, as you can see. So let me show you. This is one research paper. And the name of the research paper is Development of Multiple Combined Regression Method for Rainfall Measurement. Okay, so this is the research paper actually I have given here. So you can give any kinds of research paper, any kinds of PDF here, any kinds of PDF documents. It's up to you. Okay, so I already have this in my system. That's why I'm giving this particular PDF. Now let's see how we can extract these are the PDF text. Now what I will do, I have already created one function. So let me show you. So inside main.py, here I can mention this particular function called get documents. Okay, so first of all I will load this particular PDF. Okay, as you can see, so here I need to give the path of the PDF, copy the name. Yeah, so this is the folder. Inside that, actually whatever PDF actually you are having, it will load everything. Then after that I'm performing this recursive text splitter. That means I'm performing this chunking operation. Okay, so as you can see, so this is the chunkings actually I'm doing. After extracting the documents, I'm performing this chunking operation. That means it will create the chunks, different chunks, and this is the chunk size. That means it will take 1000 character, okay, in one chunks. Let me show you. So let's say whenever it will create this particular chunks, it will consider thousands character, okay, thousands tokens in a one chunks. Okay, so that's why you have to give this particular chunk size. And chunk overlap means how much overlap actually you want from the previous, okay, from the previous like you can say chunks you have created. Okay, so this is called chunks overlap. Now once this is done, then you have to apply this particular split document. That means it will perform the chunking. Then after that I'm just returning the documents. Then I also need to load the vector. Okay, so to load the vector, you can execute this particular function. Let me show you. You can load this particular function called get vector store. Now it will take the documents actually you have extracted. Now here I'm using this files. Okay, files vector db, as you can see, files, and I'm initializing the files. I'm giving this particular documentation, the documentation I have extracted, and I'm also giving the vector embedding. Okay, the vector embedding I have initialized. Okay, Bedrock embedding. Then what it will do, it will automatically take those other documents and it will convert to vector representation. Okay, and it will save inside my local system with the help of this particular name. Okay, files index. Now once it is done, I also need the LLM object. Okay, so I have created another function called get LLM. So here I'm initializing this particular you can say LLM. Now if you see, I'm using Meta Llama 2. Okay, so now if I show you my Bedrock, now if I go to the overview and I'm using this Llama 2 and I'm using this particular model, chat 7 billion model. Okay, now this is the model ID. Okay, just copy and here you can paste it. Okay, here you can mention now client, and here you can give the model arguments. Okay, now here I have given max gen length. Okay, that means how much actually like let's say tokens you want to get as an output, okay, from the LLM. So here I've given 512. Okay, that is 512 token it will give me as an output. And after that I'm just returning the LLM. Then what I have to do, I have to create the prompt template. So I think you remember we already defined the you can say prompt here. So prompt template. Now here I'm just defining the template. Okay, inside the template I'm just defining these other thing. Now input variable should be context and question, because here I have mentioned, okay, question and context. Now once it is done, I have to create the response function, because here it will take the input and it will give you the response. Okay, so this is the simple response function. So it will take the LLM, that means large language model, and vector store, that means your files, and query. Now first of all it will create this particular retrieval QA object. Okay, inside that it will take the LLM. Then chain type is stub, because I'm going to create a simple chain. That's why, because in LangChain there are so many chain type you can explore over the documentation. Now retriever object means your knowledge base. Okay, here I'm using the files, as you can see, vector store files and as retriever, and I'm performing similarity search. Okay, and this is the this rank result parameter. That means k is equal to 3. It will return only 3, okay, relevant answer. Then I'm just returning, okay, this particular source document as well. Then you also need to give the prompt template you have created here. Then you need to ask the query. Okay, the query actually user will give, and whatever answer actually will get, I'm just returning this particular answer. Okay, then here I just need to create a simple user application. So first of all, I'm going to create a new main method. Let me show you. So this is the main method. So here first of all I have given one title, that's a RAG demo, and here I've given the name of the project, end-to-end RAG application. Okay, then here I'm just giving one input. Okay, input text. Okay, text input from the user. So user will ask any kinds of query from the PDF itself. Now first of all what I have to do, okay, let's say if you want to ask any question on top of the knowledge base, first of all you have to build a knowledge base. That means you have to execute this particular function called get vector store. Okay, but before that you have to execute this particular function called get documents. That means it will extract the documents. After that it will store as a embedding. Okay, so I have to execute these two functions. So for this I'm going to create one button here. Okay, so let me show you. So here I'm going to create one button, as you can see. So here I'm created one slide bar, and here I've given update or create a vector store. Now if someone is clicking on this particular button, store vector, first of all it will run this particular document, that means this particular function, and it will extract the documentation, and whatever documentation actually I'm getting, okay, sorry, whatever documentation actually I'm getting from here, I'll be passing inside this particular function called get vector store. Okay, as you can see, get vector store, this documentation I'm passing. Then once it is done, I'm just sending the success message. Then if my knowledge base is created, that means vector store is created, now I'll be performing the question answer on top of it. Okay, so again I'm going to create another function. I think it should be inside this particular if statement. Yeah, so again I've created another function called send. Okay, send button. So whatever user will give the query, here, okay, first of all what I have to do, I have to load my knowledge base. Okay, as you can see, I'm loading the knowledge base, files.load actually I'm doing, and this is the index name. Then I also need to give the embedding object. Then you also need to give this particular parameter called allow dangerous deserialization is equal to 2. Okay, if you are using this file, so this is the parameter you have to pass, because I saw from the documentation they are also using this particular parameter. Then I need to load my LLM. Okay, that means I already created one function to load the LLM. So as you can see, get LLM object. Okay, then after that, here is the final function I'm calling. So get LLM response, and it will take this LLM vector store and query. So LLM vector store and query, the query actually user is asking, and I'm just writing the response. Okay, whatever response actually I'm getting, I'm writing on top of the Streamlit. Okay, now let's see whether it's working or not. So to execute this particular file, you need to run this command. So let me also mention this command. So it should be Streamlit run main.py. Okay, because I'm going to run this particular main file. Now let me copy the command, and I'm going to open up my terminal. So this is the terminal. Now I'm going to stop the previous execution. Let me clear, and let me execute this particular file. Now again this is running. So if I go back and I will close the previous one, and this is the new one, it has loaded. Okay, I'm not getting anything because let me check my code. Main.py. Okay, so this main actually I'm not calling. Okay, so I need to also define this particular main function in this particular if statement. Okay, if underscore name underscore main, then I'm going to access these are the code. Okay, now I think it should work. I'll go back and rerun this particular code. So guys, now as you can see, I got my interface. Now first of all I need to store the vector. Okay, because I need to extract the documents, I need to store the knowledge base. So let's click on this particular store vector. So once it is done, you will see the success message. So guys, as you can see, the execution is done. Now if I show you my code, left hand side you can see it has created this particular index. Okay, that means here actually it has stored all of my vector, but it is in a pickle format. Okay, because you can't visualize these are the vector. Again, it's a local vector DB. Okay, if you want to see that particular vector, you can use Pinecone. Okay, Pinecone or Weaviate. There actually you can visualize these are the vector, like how it is look like and all. Now what I will do, I'll ask some of the queries. So let's ask query with respect to the PDF actually I'm having. So let me open the PDF. So let's say I'll be asking related this particular rainfall measurements. Okay, so rainfall measurements, I'll copy this particular term, and here I can ask, so tell me about rainfall measurements. Now if I just I think I need to click on the send button. Okay, now I think it should work. Now guys, let me ask another query. So I'll ask tell me about methodology. Tell me about methodology of the paper. Now guys, here is the response I got. So guys, here is the response I got. The paper compares the performance of the various regression models for the rainfall prediction, and the methodology involves the comparing of the performance of different regression model statistical metrics such as R2 score, MAE, MSC, and RMSC. Okay, if you read this particular paper, you will see the same thing actually. They are also explaining about this particular paper and all. That means it is working fine. Okay, now not only this particular paper, you can place any kinds of actually PDF here in this particular folder. Okay, any kinds of PDF books. and you can again click on this particular button. So let me show you. So this is my application. You can again click on this particular button. That means store vector. It will again store those new vector. That means new text, and it will create a new knowledge base. And on top of that, you can perform the question answer. Okay. So this is like awesome application. Actually, you can create with the help of this particular AWS Bedrock. Okay. Not only this model, you can also use Mistral AI. Okay. You can also use this particular Stability AI. Okay. You can try these are the model at least. Okay. After this particular, you can say video, you can try with different model, and you can create different application on top of it. So yeah, guys, this is all about from this particular video. I hope you got the entire understanding how we can create a different actually application, how we can create a, you can say, end-to-end RAG application with the help of this particular AWS Bedrock. So here you can explore this particular playground as well as the model, actually different foundation model you can export, and you can create different application. Okay. So yes, guys, this is all about from this particular video, and this is like awesome actually platform they have developed. If you see the inference execution time, actually it's like very fast, although I'm using like bigger model. Let's say I used metal model, this particular 70 billion parameter model, and my execution time was like very fast there. Okay. But if you're loading this particular model on your system, you will see you will get lots of difficulty there. Okay. So yes, guys, this is all about from this particular video. I hope you like this particular video. So thank you so much, guys, for watching this video, and I'll see you next time.